Hi everyone, welcome to Simplilearn's YouTube channel. Every day, organizations generate enormous amounts of data from customers' transaction and financial reports to website traffic, healthcare records, and business operations. But raw data alone has little value unless it can be understood and transformed into meaningful insights. This is where data visualization becomes an essential skill. Data visualization is the process of representing data through charts, graphs, dashboards, maps, and interactive visuals, making it easier to identify patterns, trends, relationships, and outliers. It enables organizations to communicate complex information clearly, make faster decisions, and uncover opportunities that might otherwise remain hidden. Today, data visualization is a core skill for data analysts, business analysts, data scientists, BI developers, product managers, and business leaders. Organizations across industry rely on visualization tools to monitor performance, track KPIs, analyze customer behavior, and support data-driven decision-making. Throughout the course, you'll gain hands-on experience using popular tools such as Microsoft Excel, Tableau, Power BI, and Python libraries like Matplotlib and Plotly to create meaningful visualizations from real-world datasets. You will also learn how to choose the right visualization for different types of data, design dashboards that communicate insights effectively, avoid common visualization mistakes, and present data in a way that drives better business decisions. By the end of this course, you will have a practical skill to transform raw data into compelling visual stories that help organizations make informed decisions. That said, if these are the type of videos you'd like to watch, then hit that subscribe button with the bell icon to get notified whenever we host. Also, just so that you know, if you want to upskill yourself, master data science and data analytics skills, and land your dream job or even grow in your career, then you must explore Simplilearn's cohort of various data science and data analytics programs. Simplilearn offers a variety of master's, certification, and postgraduate programs in collaboration with some of the world's leading universities and certification boards. Through our courses, you will gain knowledge and work-ready expertise in skills like Python, Tableau, Power BI, Generative AI, and over a dozen others. And that's not all, you'll also get the opportunity to work on multiple projects led by industry experts working in top-tier data and product companies. After completing these courses, thousands of learners have transitioned into data science or data analytics role as a fresher or moved on to a higher paying job and profile. If you're passionate about making your career in this field, then make sure to check out the link in the pinned comments and in the description box to find the data science and data analytics program that fits your experience and areas of interest. So let's get started.
Companies around the world are generating vast volumes of data every hour. This data could be in the form of log files, web server and transactional data, as well as various customer-related data. Also, data is being generated at a rapid rate from social media websites and applications such as Facebook, Instagram, Twitter, and WhatsApp. Companies want to use this data to derive value out of it and make business decisions. That's where data analytics comes into use. Data analytics is the process of exploring and analyzing large data sets to find hidden patterns, unseen trends, discover correlations, and valuable insights to make business predictions. Data analytics improves the speed and efficiency of your business. A few years ago, a business would have gathered information manually, performed statistical and complex analytics, and unearthed information that could be used for future decisions. But today, that business can identify insights on the fly for immediate decisions. Most organizations have big data, and many understand the need to harness that data and extract value out of it. So, they use a lot of modern tools and technologies to perform data analytics. Some of the tools I will discuss in detail later in this tutorial.
Moving on, who is a data analyst? A data analyst collects, analyzes, and interprets data. A data analyst will convert raw data into useful information. Data analysts are in high demand because every industry uses data analysis. Work of a data analyst. As a data analyst, you will work closely with the raw data and generate valuable insights to help companies decide their future goal. If you like thinking out of the box, you are the perfect fit for this domain. Data analysts help maximize output when it comes to generating revenue, working closely with both business and data. Nevertheless, this field boasts handsome salaries for all levels of expertise. Can you become a data analyst without prior experience? Yes, anyone can become a data analyst if they enjoy solving real world problems, have a strong background in statistics, and have a creative mind. If you feel you don't have it, you can definitely develop it. So let us know the skills in detail. What are the basic skill sets required for a data analyst? Data analyst must know basic mathematics and statistics, programming skills, machine learning, and also data visualizations tools. So let us know what are the basics that you need to learn as a data analyst. Mathematics. It is always better to know basic mathematics like linear algebra and probability fundamentals. Linear algebra is used in data pre-processing and transformation, which is the critical process of every data analyst. Statistics, a branch of mathematics that deals with collection, analysis, presentation, and implementation. Probability. We know that probability is the study of how likely something will happen, which is essential for concluding. Both probability and statistics are the backbones of data analysis. It is feasible to become a data analyst with only a basic understanding of these three areas of mathematics. But in order to remain relevant and grow as a data analyst, one's mathematical knowledge should not be restricted. Compulsorily use some of the tools as a data analyst. What are that? First is Microsoft Excel. It is the most well-known spreadsheet software in the world. It also has computation and graphing features that are excellent for data analysts. No matter your area of expertise or additional software you might want, Excel is a standard in the industry. Its useful built-in features include form design tools and pivot table. It also generates a wide range of additional features that help simplify data manipulation. As a programming language, every data analyst should know Python. It is easy to learn and has a simple syntax. Python is quite adaptable and includes a vast variety of resource libraries that are appropriate for a wide range of diverse data analytics activities. These libraries help in numerical and data computation. The Pandas and NumPy libraries, for instance, are excellent for supporting standard data processing and streamlining highly computational operations. You can also choose between Python or R. R is a well-known open source programming language much like Python. Data visualization tool. As we previously mentioned, data visualization tool is also necessary to become a data analyst. Power BI is a user-friendly interface, makes building interactive visual reports and dashboards simple. Its most vital selling point is its superb data integration. It works flawlessly with cloud sources like Google and Facebook Analytics, as well as text files, SQL servers, and Excel. Tableau is one of the best commercial data analysis tool available. It handles huge amounts of data better than many other BI tools and is effortless. It has a visual drag and drop interface. However, because it has no scripting layer, there is a limit to what Tableau can do. For example, it could be better for pre-processing data or building more complex calculations. You might have heard about MySQL a lot of time. It is a standard language for interacting with databases, and it is very helpful when working with structured data. SQL creates user-friendly dashboards that may present in various data ways since it is so simple to send complex commands to databases and change data in seconds. It has commands like add, edit, delete data. In addition, SQL is an excellent tool for creating data warehouses because of its simplicity, clarity, and interactivity. Overall, I would suggest that to become a data analyst, you should work on programming languages like Python or R plus MySQL to work on databases, adding to that Excel plus visualization tools like Tableau or Power BI. You now know what are the skills are and how it is used. What are you up to in an organization as a data analyst? To create and evaluate the report using automated tools like Tableau or Power BI. To troubleshoot the reporting database environment and reports. Data analyst, you will use statistical method to analyze data sets and spot any valuable trends that may develop over time. Evaluate companies' functional and non-functional requirements. Data analyst assess data warehousing in inspecting and reporting needs. These are all the responsibility of a data analyst in an organization. Coming to Companies hiring a data analyst. IBM, Accenture, Capgemini, TCS, Facebook, Amazon, Flipkart, Meta. These are the top companies hiring a data analyst. But data suggests that every small and medium-sized company needs a data analyst. Therefore, demand of a data analyst is in every company. So, there is no need to worry. Job and salary of a data analyst. This is the final part. The salary of a data analyst is high all over the world. When it comes to the USA, the average salary for a data analyst as a beginner is going as high as $70,000 plus per annum. For experienced professional, it is going as high as $120,000 per annum. In India, for a fresher, it is going as high as 8 lakh per annum, and for experienced professionals, it is 20 lakh plus per annum. Such is the demand for data analyst. Now that we have covered every important skill, it's time for you to start working on it.
So, sky's the limit on what you use it for. Let's take a look at types of data analytics. And this can be broken up in so many ways, but we're going to start with looking at the most basic questions that you're going to be asking in data analytics. And the first one is you want descriptive analytics. What has happened? Hindsight. How many sales per call ratio coming out of the call center? If we have 500 tourists in a forest and you have a certain temperature, how many fires were started? How many times did the police have to show up to certain houses? All that's descriptive. The next one is predictive. Predictive analytics is what will happen next. We want to predict. This is great if you have an ice cream store and you want to predict how many people to work at the ice cream store on a certain day based on the temperature coming up in the time of the year. And then one of the biggest growing and most important parts of the industry is now prescriptive analytics. And you can think of that as combining the first two. We have descriptive and we have predictive, and then you get prescriptive analytics. How can we make it happen? Foresight. What can we change to make this work better? In all the industries we looked at before, we can start asking questions, especially in city development. There's a good one. If we want to have our city generate more income, and we want that income to be commercial based, what kind of commercial buildings do we need to build in that area that are going to bring people over? Do we need huge warehouse cells, Costco sales buildings, or do we need little mom and pop joints that are going to bring in people from the country to come shop there? Or do you want an industrial setup? What do you need to bring that industry in there? Is there a car industry available in that area? If it's not a car industry, what other industries are in that area? All those things are prescriptive. We're guessing. We're guessing what can we do to fix it? What can we do to fix crime in an area with education? What kind of education are we going to use to help people understand what's going on so that we lower the rate of crime and we help our communities grow better? That's all prescriptive. It's all guessing. We want foresight into how can we make it happen? How can we make this better? And we really can't not go into enough detail on these three, because a lot of people stumble on this when they come in and are doing analytics. Whether you're the manager, shareholder, or the data scientist coming in, you really need to understand the descriptive analytics, where you're studying the total units of furniture sold and the profit that was made in the past. Here we go into predictive analytics, predicting the total units that would sell and the profit we can expect in the future, gear up for how many employees we need, how much money we're going to make, and prescriptive analytics, finding ways to improve the sales and the profit so we can sell maybe a different kind of furniture. We're going to guess at what the area is looking for and how that marketing is going to change.
Hello everyone, we welcome you all to this video by Simplilearn. In today's session, we will learn a really interesting topic, that is the top 10 skills to become a data analyst in 2022. In today's digital world, data is being generated by companies and individuals every second, so the role of a data analyst holds supreme importance. So if you're looking for a career in data analytics, this video will help you learn what a data analyst does and the various skills you need to possess to become a data analyst in 2022. Before we get started, make sure you subscribe to the Simplilearn channel and hit the bell icon to never miss an update from us. Let's look at the agenda for this video. First, we will understand who a data analyst is. Then we will understand the top 10 data analyst skills for 2022. Moving on, we will look at the salary of a data analyst.
And finally, we will look at the companies hiring data analysts. So now let's understand who is a data analyst. A data analyst is a professional who collects business data from various sources, interprets it, and uses various statistical tools and techniques to extract insights and useful information from it. They acquire data from primary or secondary data sources and maintain databases. They also recognize and understand the organization's goal and collaborate with different team members such as programmers, business analysts, and data scientists to build an effective solution to a business problem. Now, with this basic understanding of who a data analyst is, let's learn the top 10 data analyst skills for 2022. At number 1, we have Structured Query Language or SQL. SQL is a top skill that every data analyst should have. Data analysts use SQL commands and functions to store, process, analyze, and manipulate structured data using relational and NoSQL databases. They also build data models and write complex SQL queries and scripts to gather and extract information from several databases and data warehouses. Some of the popular databases a data analyst should be familiar with are Microsoft SQL Server, MySQL, PostgreSQL, and IBM DB2. The second important skill for a data analyst is Microsoft Excel. Microsoft Excel is one of the most popular and oldest spreadsheet applications for creating reports, performing calculations, and analyzing data. Data analysts need to know how to handle tabular data in Excel. So, they should be aware of features like sorting, filtering, conditional formatting, pivot tables, what-if analysis, and functions such as SUMIFs and COUNTIFs. The third crucial data analyst skill for 2022 is data cleaning and wrangling. Usually, the data collected by analysts from various heterogeneous sources is often messy and contains a lot of missing values. So, it is always crucial to clean the data and remove noise, missing, or erroneous elements. It is also important to format data using tools and methods before using it for analysis. They are responsible for data mining as well. The data mined from various sources are organized in order to obtain new information from it. Some of the tools you need to know for data cleaning and wrangling are Excel Power Query and OpenRefine. The fourth skill on our list is mathematics and statistics. Data analysts often work on data for higher dimensions that are greater than 3. In order to interpret such data, they need to be good at linear algebra and calculus. They also build predictive models and statistical models such as linear regression, logistic regression, naive Bayes, and k-means clustering. In order to understand the working of these algorithms, they must have knowledge about statistics and probability. Coming to the fifth important skill for a data analyst in 2022, we have programming. Data analysts need to master at least one programming language, preferably Python or R. In order to work with complex business problems, analysts need to write scripts and user-defined functions to automate tedious tasks. Python and R language provide a collection of different libraries and packages such as NumPy, Pandas, dplyr, matplotlib, ggplot, which data analysts can use to discover trends and patterns from complex data sets. After this, we have data visualization as our sixth skill. Another data analyst job role is to visualize large volumes of data and prepare summary reports and dashboards for the leadership team and clients so that they can make timely business decisions. To do this, data analysts use various data visualization tools such as Power BI, Tableau, and QlikView. Using these tools, data analysts can integrate various data sets, apply joint conditions, sort and filter data, as well create different visualizations using charts and graphs. The seventh skill for a data analyst is industry knowledge. Data analysts should have good knowledge and understanding of the industry or domain they are working in. For example, if you're working in a healthcare domain, you need to know how healthcare analytics can be applied to improve patient care. You should have knowledge about the challenges faced in healthcare and how you can leverage data and analytics to solve the issues. Only if you have strong industry knowledge can you try to improve the business. The eighth skill that is important for a data analyst in 2022 is problem solving. A business deals with several problems on a daily basis. Data analysts should be ready to face those challenges. Data analysts are expected to use their problem-solving skills, work with the team, troubleshoot what went wrong, and provide an effective solution via data analysis. A data analyst with good problem-solving skills can help a business identify current and potential issues and determine a viable solution based on the data it collects. The ninth skill on our list is analytical thinking. Data analysts need analytical thinking ability to break down a complex problem into simple components and resolve these components one by one. It is a must-have skill for data analysts. Analytical thinking includes deciding the parameters that need to be considered for defining data sets, analyzing them from different perspectives, and determining variable dependencies. Coming to the 10th skill among the top 10 skills for a data analyst in 2022, we have communication. Data analysts don't just interact with computers and programs, they also interact with team members, stakeholders, and data suppliers. So, good communication skills are essential. Data analysts also present their findings in front of an audience who might not be familiar with the analytical methods and processes. So they need to clearly translate their findings and insights into non-technical terms. So those were the top 10 skills a data analyst needs to possess in 2022. Do you think we missed out on any skills? Then please put your answers in the comment section below. Now let's look at the salary of a data analyst. According to Glassdoor, the average annual salary for a data analyst in the United States is $69,517. While in India, you can earn nearly 7 lakh rupees per annum. Finally, let's look at the top companies that are hiring data analysts in 2022. Here we have the consultancy and Big Four giant Deloitte and the pharmaceutical company Cerner Corporation. Then we have the tech giant IBM, retail company Walmart, and the e-commerce leader Amazon. To achieve the goals of data analysis, we use a number of data analysis tools. Companies rely on these tools to gather and transform their data into meaningful insights. So which tool should you choose to analyze your data? Which tool should you learn if you want to make a career in this field? We will answer that in this session. After extensive research, we have come up with these top 10 data analysis tools. Here, we will look at the features of each of these tools and the companies using them. So let's start off. At number 10, we have Microsoft Excel. All of us would have used Microsoft Excel at some point, right? It is easy to use and one of the best tools for data analysis. Developed by Microsoft, Excel is basically a spreadsheet program. Using Excel, you can create grids of numbers, text, and formulae. It is one of the widely used tools, be it in a small or large setup. The interface of Microsoft Excel looks like this. Let's now move on to the features of Excel. Firstly, Excel works with the Windows version of Excel supports programming through Microsoft's Visual Basic for Applications (VBA). Programming with VBA allows spreadsheet manipulation that is difficult with standard spreadsheet techniques. In addition to this, the user can automate tasks such as formatting or data organization in VBA. One of the biggest benefits of Excel is its ability to organize large amounts of data into orderly logical spreadsheets and charts. By doing so, it's a lot easier to analyze data, especially while creating graphs and other visual data representations. The visualization can be generated from a specified group of cells. Those were few of the features of Microsoft Excel. Let's now have a look at the companies using it. Most of the organizations today use Excel. Few of them that use it for analysis are the UK-based company Ernst & Young. Then we have Urban Pro, Wipro, and Amazon. Moving on to our next data analysis tool, at number 9, we have RapidMiner. A data science software platform, RapidMiner provides an integrated environment for data preparation, analysis, machine learning, and deep learning. It is used in almost every business and commercial sector. RapidMiner also supports all the steps of the machine learning process. Seen on your screens is the interface of RapidMiner. Moving on to the features of RapidMiner. Firstly, it offers the ability to drag and drop. It is very convenient to just drag drop some columns as you are exploring a data set and working on some analysis. RapidMiner allows the usage of any data, and it also gives an opportunity to create models which are used as a basis for decision making and formulation of strategies. It has data exploration features such as graphs, descriptive statistics, and visualization, which allows users to get valuable insights. It also has more than 1,500 operators for every data transformation and analysis task. Let's now have a look at the companies using RapidMiner. We have the Caribbean airline Leeward Islands Air Transport. Next, we have the United Health Group, the American online payment company PayPal, and the Austrian telecom company Mobilcom. So that was all about RapidMiner. Now let's see which tool we have at number 8. We have Talent at number 8. Talent is an open source software platform which offers data integration and management. It specializes in big data integration. Talent is available both in open source and premium versions. It is one of the best tools for cloud computing and big data integration. The interface of Talent is as seen on your screens. Moving on to the features of Talent. Firstly, automation is one of the great boons Talent offers. It even maintains the tasks for the users. This helps with quick deployment and development. It also offers open source tools. Talent lets you download these tools for free. The development costs reduce significantly as the processes gradually speed up. Talent provides a unified platform. It allows you to integrate with many databases, SaaS, and other technologies. With the help of the data integration platform, you can build flat files, relational databases, and cloud apps 10 times faster. Those were the features of Talent. The companies using Talent are Air France, L'Oreal, Capgemini, and the American multinational pizza restaurant chain Domino's. Next on the list at 7 we have NIME. Constance Information Miner on NIME is a free and open source data analytics, reporting, and integration platform. It can integrate various components for machine learning and data mining through its modular data pipelining concept. NIME has been used in pharmaceutical research and other areas like CRM customer data analysis, business intelligence, text mining, and financial data analysis. Here is how the interface of NIME application looks like. Now coming to the NIME features. NIME provides an interactive graphical user interface to create visual workflows using the drag and drop feature. Use of JDBC allows assembly of nodes blending different data sources, including pre-processing such as ETL, that is extraction, transformation, loading, for modeling, data analysis, and visualization with minimal programming. It supports multi-threaded in-memory data processing. NIME allows users to visually create data flows, selectively execute some or all analysis steps, and later inspect the results, models, and interactive views. NIME Server automates workflow execution and supports team-based collaboration. NIME integrates various other open source projects such as machine learning algorithms from Beca, H2O, Keras, Spark, and our project. NIME allows analysis of 300 million custom addresses, 20 million cell images, and 10 million molecular structures. Some of the companies hiring for NIME are United Health Group, ASML, Fractal Analytics, Atos, and Lego Group. Let's now move on to the next tool. We have SAS at number 6. SAS facilitates analysis, reporting, and predictive modeling with the help of powerful visualizations and dashboards. In SAS, data is extracted and categorized, which helps in identifying and analyzing data patterns. As you can see on your screens, this is how the interface looks like. Moving on to the features of SAS. Using SAS, better analysis of data is achieved by using automatic code generation and SAS SQL. SAS allows you to access through Microsoft Office by letting you create reports using it and by distributing them through it. SAS helps with an easy understanding of complex data and allows you to create interactive dashboards and reports. Let's now have a look at the companies using SAS. We have companies like Genpact, IQVIA, Accenture, and IBM to name a few. That was all about SAS. So for all those who joined in late, let me just quickly repeat our list. At number 10, we have Microsoft Excel. Then at number 9, we have RapidMiner. At number 8, we have Talent. At number 7, we have 9. And at number 6, we have SAS. So far, do you all agree with this list? Let us know in the comment section below. Let's now move on to the next 5 tools in our list. So at number 5, we have both R and Python. Yes, we have 2 of them in the 5th position. R is a programming language which is used for analysis as well. It has traditionally been used in academics and research. Python is a high-level programming language which has a Python data analysis library. It is used for everything starting from importing data from Excel spreadsheets to processing them for analysis. This is the interface of R. Next up is the interface of the Python Jupyter Notebook. Let's now move on to the features of both R and Python. When it comes to the availability of R and Python, it is very easy. Both R and Python are completely free, hence it can be used without any license. R used to compute everything in memory and hence the computations were limited, but now it has changed. Both R and Python have options for parallel computations and good data handling capabilities. As mentioned earlier, as both R and Python are open in nature, all the latest features are available without any delay. Moving on to the companies using R, we have Uber, Google, Facebook, to name a few. Python is used by many companies. Again, to name a few, we have Amazon, Google, and the American photo and video sharing social networking service, Instagram. That was all about R and Python. At number 4, we have Apache Spark. Apache Spark is an open source engine developed specifically for handling large-scale data processing and analytics. Spark offers the ability to access data in a variety of sources including Hadoop Distributed File System HDFS, OpenStack Swift, Amazon S3, and Cassandra. It allows you to store and process data in real time across various clusters of computers using simple programming constructs. Apache Spark is designed to accelerate analytics on Hadoop while providing a complete suite of complementary tools that include a fully featured machine learning library, a graph processing engine, and stream processing. So this is how the interface of Apache Spark looks like. Now let's look at the important features of Apache Spark. Spark stores data in the RAM, hence it can access the data quickly and accelerate the speed of analytics. Spark helps to run an application in a Hadoop cluster up to 100 times faster in memory and 10 times faster when running on disk. It supports multiple languages and allows the developers to write applications in Java, Scala, R, or Python. Spark comes up with 80 high-level operators for interactive querying. Spark code for batch processing, join stream against historical data, or run ad hoc queries on stream state. Analytics can be performed better as Spark has a rich set of SQL queries, machine learning algorithms, complex analytics, etc. Apache Spark provides fault tolerance through Spark RDD. Spark resilient distributed data sets are designed to handle the failure of any worker node in the cluster. Thus, it ensures that the loss of data reduces to 0. Conviva, Netflix, IQVIA, Lockheed Martin, and eBay are some of the companies that use Apache Spark on a daily basis. At number 3, we have another important growing data analysis tool, that is QlikView. QlikView software is a product of Qlik for business intelligence and data visualization. QlikView is a business discovery platform that provides self-service BI for all business users and organizations. With ClickView, you can analyze data and use your data discoveries to support decision making. ClickView is a leading business intelligence and analytics platform in Gartner Magic Quadrant. On the screen, you can see how the interface of ClickView looks like. Now talking about its features. ClickView provides interactive guided analytics with in-memory storage technology. During the process of data discovery and interpretation of collected data, the ClickView software helps the user by suggesting possible interpretations. ClickView uses a new patent in-memory architecture for data storage. All the data from the different sources is loaded in the RAM of the system and it is ready to be retrieved from there. It has the capability of efficient social and mobile data discovery. Social data discovery offers to share individual data insights within groups or out of it. A user can add annotations as an addition to someone else's insights on a particular data report. ClickView supports mobile data discovery within an HTML5-enabled touch feature which lets the user search the data and conduct data discovery interactively and explore other server-based applications. ClickView performs OLAP and ETL features to perform analytical operations, extract data from multiple sources, transform it for usage, and load it to a data warehouse. The companies that can help you start your career in ClickView are Mercedes-Benz, Capgemini, Citibank, Cognizant, and Accenture, to name a few. At number 2, we have Power BI. Power BI is a business analytics solution that lets you visualize your data and share insights across your organization or embed them in your app or website. It can connect to hundreds of data sources and bring your data to life with live dashboards and reports. Power BI is the collective name for a combination of cloud-based apps and services that help organizations collate, manage, and analyze data from a variety of sources through a user-friendly interface. Power BI is built on the foundation of Microsoft Excel and has several components such as Windows desktop application called Power BI Desktop and online software as a service called Power BI Service, mobile Power BI apps available on Windows phones and tablets, as well as for iOS and Android devices. Here is how the Power BI interface looks like. As you can see, there is a visually interactive sales report with different charts and graphs. Moving on to the features of Power BI. It has an easy drag and drop functionality with features that make data visually appealing. You can create reports without having the knowledge of any programming language. Power BI helps users see not only what's happened in the past and what's happening in the present, but also what might happen in the future. It offers a wide range of detailed and attractive visualizations to create reports and dashboards. You can select several charts and graphs from the visualization pane. Power BI has machine learning capabilities with which it can spot patterns in data and use those patterns to make informed predictions and run what-if scenarios. Power BI supports multiple data sources such as Excel, Text CSV, Oracle, SQL Server PDF, and XML files. The platform integrates with other popular business management tools like SharePoint, Office 365, and Dynamics 365, as well as other non-Microsoft products like Spark, Hadoop, Google Analytics, SAP, Salesforce, and MailChimp. Some of the companies using Power BI are Adobe, AXA, Carlsberg, Capgemini, and Nestle. Moving on to the next tool. So any guesses as to what we have at number 1? You can comment in the chat section below. Finally, on the top of the pyramid, we have Tableau. Gartner's Magic Quadrant of 2020 classified Tableau as a leader in business intelligence and data analysis. Tableau Interactive Data Visualization Software Company was founded in Jan 2003 in Mountain View, California. Tableau is a data visualization software that is used for data science and business intelligence. It can create a wide range of different visualization to interactively present the data and showcase insights. The important products of Tableau are Tableau Desktop, Tableau Public, Tableau Server, Tableau Online, and Tableau Reader. This is how the interface of Tableau Desktop looks like. Now coming to the features of Tableau. Data analysis is very fast with Tableau, and the visualizations created are in the form of dashboards and worksheets. Tableau delivers interactive dashboards that support insights on the fly. It can translate queries to visualizations and import all ranges and sizes of data. Writing simple SQL queries can help join multiple data sets and then build reports out of it. You can create transparent filters, parameters, and highlighters. Tableau allows you to ask questions, spot trends, and identify opportunities. With the help of Tableau Online, you can connect with cloud databases, Amazon Redshift, and Google BigQuery. The companies using Tableau are Deloitte, Adobe, Cisco, LinkedIn, and the American e-commerce giant Amazon, to name a few. And there you go, those are the top 10 data analysis tools.
R is a statistical programming language and environment that integrates statistical computing and graphics. R is powerful and stable software. Python can also be called as a general-purpose programming language for data analysis and scientific computing. Python can be considered as the best player in machine learning. Python is an expressive language with many built-in functions. Both are open source software and platform independent. And they are platform neutral and also compatible with all major operating systems including Unix, Windows, and Mac. Next, we will be covering different parameters. We will be covering learning preferability, mathematical fundamentals, speed of both the languages, visualization and graphics, data handling capacity, demand, community and customer support, employment possibility in both the languages. Let us cover it one by one. First one is learning preferability or ease of learning. Python is renowned for its ease of use. Python's notebooks offer excellent tools for sharing and documentation despite the fact that there are currently no GUIs for them. Programmers find R as difficult language as a beginner. This implies that the programmers must devote a significant amount of time to learn and comprehending R coding. Coming to mathematical fundamentals required. Coming to Python, understanding descriptive analysis is very important. In layman's terms, descriptive statistics often refers to the process of explaining using certain representative techniques such as charts, tables, Excel files, etc. Python statistics is a built-in library for descriptive statistics. If your data sets are not too big or if you can't rely on importing other libraries, you can use Python. On the other hand, R requires basic statistics. From basic statistics, what I mean is mean, mode, and median are the terms used most frequently in basic statistics. It is referred to as measures of central tendency. Probability statistics plays an important role in handling various types of probability distribution. It includes binomial and normal distribution. Next parameter is speed. Python is an interpreted language with dynamic typing. Python always executes slowly because the code is executed line by line. Compared to MATLAB and Python, R language is significantly slower. R packages are substantially slower than those for other languages. Now that we have covered speed, coming to data visualization and data collection in Python. When selecting data analysis tools, visualization are crucial and Python has some incredible visualization tools. In Python, to large and varied scatter plots using regression lines, we can use ggplot2 and ggplot tools. Compared to raw values, visualized data is easier to comprehend. Therefore, R has many packages that offers sophisticated graphic features. In R, we can use tools like matplotlib, seaborn, etc. Data handling capability in both Python and R. The new releases in Python have resolved the issue with the Python packages for data analysis. R is useful for analysis because of the abundance of packages, accessibility of the test, and benefit of employing formulas. However, simple data analysis can also be done using the need to install many packages. Crucial part of parameter, that is tools and libraries in Python and R. As a Python developer, one needs to be well versed in the best libraries because Python has a lot of libraries that have many different uses. Libraries like TensorFlow, Scikit-learn, NumPy plays an important role in solving many Python-related problems. Libraries perform a wide variety of tasks in R that are very beneficial for data science operations. Example for that is dplyr, bioconductor, etc. Community and customer support index offered by Python and R. Compared to R, Python has a larger community. For assistance, we can contact www.python.org. For any queries regarding Python and help, you can you can visit support.realpython.com. For any help and queries, R offers you with RStudio community. R provides assistance through its official website. For queries and community related issues, we can contact www.r-project.org. Next is job opportunities in Python and R. A recent survey from Indeed.com predicts that at least 55,000 Python jobs in the USA with exponential pay rates are available. Big tech companies like Google, Amazon, Twitter, Facebook requires Python developer to handle massive amount of data. Position provided for a Python developer is software engineer, data analyst, data scientist, and many more. Career in R is an excellent job opportunity for you as a beginner. Big tech companies like Google, Twitter, Facebook are using R. Position provided by companies as a R developer is data scientist, data analyst, data visualization analyst, etc. Moving on, let us wrap up an important topic, which language to be used between R and Python. There is no right or wrong way to study both Python or R. Both are in demand skills that will enable you to complete almost any data analytics work you come across. It ultimately depends on your background, interest, and career objectives that which one is better for you. But compared to R, Python is easy to learn. Let's compare its strengths and weaknesses. It is used to handle large amount of data. Python performs non-statistical functions and it is best suitable for programming. However, Python is better when it comes to coding. Whereas R is used in data visualization graphics, R is a widespread language in the statistical community. It is used to accomplish many mathematical tasks. So before concluding the topic, let me answer the query that I have asked regarding R and Python. Do you guys remember the question? The query was, R language is superficially related to which language? So the answer for the question is C language.
If you categorize the steps to become a data analyst, these are the ones. Firstly, you need to focus on skills. Followed by that, you need to have a proper qualification. Then test your skills by creating a personal project, an individual project. Followed by that, you must focus on building your own portfolio to describe your caliber to your recruiters. And then target to the entry level jobs or internships to get exposure to the real world data problems. So these are the 5 important steps. Now let's begin with the step 1, that is skills. So skills are basically categorized into 6 steps: data cleaning, data analysis, data visualization, problem solving, soft skills, and domain knowledge. So these are the tools: Excel, MySQL, R programming language, Python programming language, some data visualization tools like Tableau, Power BI, and next comes the problem solving. So these are basically the soft skill parts. Problem solving skills, domain knowledge, the domain in which you're working, maybe a pharma domain, maybe a banking sector, maybe automobile domain, etc. And lastly, you need to be a good team player so that you can actively work along with the team and solve the problem collaboratively. Now, let's move ahead and discuss each and every one of these in a bit more detail. Starting with Microsoft Excel. While advanced tools are prevalent, proficiency in Excel remains vital for data analysts. Excel versatility in data manipulation, visualization, and modeling is unmatched. It serves as a foundational tool for initial data exploration and basic analysis. Data management. Database management skill is indispensable for data analysts. As data volumes soar, efficient management and retrieval from databases is critical. Proficiency in database systems and querying languages like SQL ensures analysts can access and manipulate data seamlessly. Followed by that, we have statistical analysis. Statistical analysis allows analysts to uncover hidden trends, patterns, and correlationships within data, facilitating evidence-based decision making. It empowers analysts to identify the significance of findings, validate hypotheses, and make reliable predictions. Next, after that, we have programming languages. Proficiency in programming languages like Python is essential for data analysts. These languages enable data manipulation, advanced statistical analysis, and machine learning implementations. Next comes data storytelling, or also known as data visualizations. Data storytelling skill is paramount for data analysts. Data storytelling bridges the gap between data analysis and actionable insights, ensuring that the value of data is fully realized in a world where data-driven communication is central to business success. Data visualization skill is a cornerstone for data analysts. As data complexity grows, the ability to present insights clearly and persuasively is paramount. Next is managing your customers and problem solving. Managing all your customers' data and companies' relationships is paramount. Strong problem solving skills are important for data analysts with complex data challenges and evolving analytical methodologies. Analysts must excel in identifying issues, formulating hypotheses, and devising innovative solutions. In addition to the technical skills, data analysts in 2025 will require strong soft skills to excel in their roles. Here are the top ones. Data analysts must effectively communicate their findings to both technical and non-technical stakeholders. This includes presenting complex data in a clear and understandable manner. Next soft skill is teamwork and collaboration. Data analysts often work with multidisciplinary teams alongside data scientists, data engineers, business professionals. Collaborative skills are essential for sharing insights, brainstorming solutions, and working cohesively towards common goals. And last but not least, domain knowledge. Knowledge on domain in which you're currently working is really important. It might be a pharmaceutical domain, it can be an automobile domain, it can be banking sector, and much more. Unless you have a basic foundational domain knowledge, you cannot continue in that domain with accurate results. Now, the next step, which was about the qualification to become a data analyst. Master's courses, online courses, and boot camps provide strong, structured learning that helps you gain in-depth knowledge and specialized skills in data analysis. Master's programs offer comprehensive, academically rigorous training and often include research projects, making sure you're highly competitive in the job market. Online courses allow flexibility to learn at your own pace while covering essential topics, and boot camps offer immersive, hands-on training in a short period focusing on practical skills. All three paths enhance your credibility, keeping you updated on industry trends and make you more attractive to potential employers. If you are looking for a well-curated all-rounder, then we have got you covered. Simplilearn offers a wide range of courses on data science and data analytics, starting from master's, professional certifications, to post-graduations and boot camps from globally reputed and recognized universities. For more details, check out the links in the description box below and comment section. Now, proceeding ahead, we have the projects for data analyst. Data analyst projects demonstrate practical skills in data cleaning, visualization, and analysis. They help build a portfolio showcasing your expertise and problem-solving abilities. Projects provide hands-on experience bridging the gap between theory and real-world application. They show domain knowledge, making you more appealing to employees in specific industries. Projects enhance your confidence and prepare you to discuss real-world challenges in interviews. Proceeding ahead, the next step is about the portfolio for data analysts. A portfolio is a testament that demonstrates your skill and expertise through real-world projects, showcasing your ability to analyze and interpret data effectively. It provides tangible proof of your capabilities, making you stand out to the employers. Additionally, it highlights your domain knowledge and problem-solving skills, giving you a competitive edge during job applications and interviews. Last but not the least, data analyst internships. Internships provide hands-on experience with real-world datasets, tools, and workflows, bridging the gap between theory knowledge and practical application. They offer exposure to industry practices, helping you understand how data is used to drive decisions. Internships also build your professional network, enhance your resume, and improve chances of securing a full-time data analyst role.
What's in it for you? Now we're going to go over what is NumPy, installing and importing NumPy, NumPy array versus Python list, basics of NumPy, finding size and shape of any array, range and arrange functions, NumPy string functions. And then in part 2, I'll move on to cover axes, array manipulation, and much more. So let's start with what is NumPy. NumPy is the core library for scientific and numerical computing in Python. It provides high-performance, multi-dimensional array object and tools for working with arrays. And I'll go a step further and say there are so many other modules in Python built on NumPy. So the fundamentals of NumPy are so important to latch onto for the Python so that you can understand the other modules and what they're doing. NumPy's main object is a multi-dimensional array. It is a table of elements, usually numbers, all of the same type, indexed by a tuple of position integers. In NumPy, dimensions are called axes. Take a one-dimensional array, or we have, and remember dimensions are also called axes, so you can say this is the first axis, 0, 1, 2, 3, 4, 5. And you can see down here it has a shape of 6. Why? Because there's 6 different elements in it in the one-dimensional array. And they usually denote that as 6 comma with an empty node on there. And then we have a two-dimensional array where you can see 0, 1, 2, 3, 4, 5, 6, 7. And in here we have 2 axes or 2 dimensions, and the shape is 2, 4. So if you were looking at this as a matrix or in other mathematical functions, you can see there's all kinds of importance on shape. We're not going to cover shape today, but we will cover that in part 2. Did you know that NumPy's array class is called NDArray for NumPy Data Array? Now we're going to take a detour here because we're working in Python, and 2 of my favorite tools in Python is the Jupyter Notebook, and then I like to use that sitting on top of Anaconda. And if you flip over to jupyter.org, that's jupyter.org, you can go in here. You can install it off of here if you don't want to use the Anaconda notebook, but this is the Jupyter setup, the documentation on the Jupyter. Jupyter opens up in your web browser. That's what makes it so nice, is it's portable. The files are saved on your computer. They do run in IPython or IronPython, and you can create all kinds of different environments in there, which I'll show you in just a minute. I myself like to use Anaconda. That's www.anaconda.com. If you install Anaconda, it will install the Jupyter Notebook with the Anaconda separate. And you can install Jupyter Notebook and it'll run completely separate from Anaconda's Jupyter Notebook. And you can see here I've now opened up my Anaconda Navigator. What I like about the Navigator, and this is a fresh install on a new computer, which is always nice, I can launch my Jupyter Notebook from in here. I can bring other tools, so the Anaconda does a lot more. And under environments, I only have the one environment, and I can open up the terminal specific to this environment. This one happens to have Python 3.7 in it, the most current version as of this tutorial. And then you open a terminal if you're going to do your pip installs and stuff like that for different modules. You can also create different environments in here. So maybe you need a Python 3.6, Python 3.5. You can see we're having a nice framework like Anaconda really helps. So you don't have to track that on your own in the Jupyter Notebook and your different Jupyter Notebook setups. We'll go ahead and launch this Jupyter Notebook. And then I've set my browser window for a default of Chrome. So it's going to open up in Chrome. And you can see here, this opens up a folder on my computer. We have a couple different options on here. Remember, I set the environment up as Python 3.7. You would install any additional modules that aren't already installed in your Python on this. And it keeps them separate, so you do have to, for each environment, install the separate modules so they match the environment on there. And in here we have a couple things where you can look up what's running. You have your different clusters. Again, I just installed this on a new machine, so I just have a couple things in here that were run on here recently. And where we go on here is we then have on the upper right, New, and from the pull down menu you'll see Python 3, and this will open up a new window. And now we're in Jupyter Python, so this is a Python window, and we'll just do a print. And this, of course, let's go hello world. And we'll run that and it prints out hello world in the command line. There's a couple special things you have to know what we're not going to do today, which is on graphics. If you've never seen this, one of the things you can do is you can also do A equals hello world. And if you just put the A in there, now if you do a bunch of these where you have A equals hello world, B equals goodbye world, and you put A, B, A, then return B, it'll only run the last one. But you can see here, if you put the variable down here, it will show you what's in that variable. And that has to do with the Jupyter Notebook inline coding. So that's not basic Python, that's just Jupyter Notebook shorthand, which you'll see in a little bit. So back to our NumPy array versus Python list. Python list being the basic list in your Python. Why should we use NumPy array when we have Python list? Well, first, it's fast. The NumPy array has been optimized over years and years by multiple programmers, and it's usually very quick compared to the basic Python list setup. It's convenient, so it has a lot of functionality in there that's not in the basic Python list. And it also uses less memory, so it's optimized both for speed and memory use. And let's go ahead and jump into our Jupyter Notebook. Since we're coding, the best way to learn coding is to code. Just like the best way to learn how to write is write, and the best way to learn how to cook is cook. So let's do some coding here today.
But before we move on, let's understand first what is Jupyter Notebook. So guys, as you can see all over here, that Jupyter Notebook is a popular open source tool that basically allows you to create and share documents which contains codes, equations, you can have visualizations also. Basically, it is used for data analysis, machine learning, and scientific research, which makes it a very essential tool for developers like data scientists and researchers alike. Now, before installing Jupyter Notebook, I request you that you have Python installed in your system. So the requirement should be Python 3.6 or greater. So now let us officially navigate to the Python's website. So guys, as you can see all over here, so on python.org, if I click on download Python, so we're going to see that all over here, download Python 3.125. So as I already told you that the requirement of Python should be greater than 3.6. So just you can click all over here and you can see the download had started. So guys, as you can see all over here that we have installed the Python. Now let us open the file. So you can see the given software is going to install on this directory. Okay, so just click all over here. So guys, as you can see all over here, the Python installation of 3.125 is in progress. Let's wait for some time till it gets installed. So as you can see guys all over here that we have successfully installed our Python. Now let us open our terminal and let us check whether Python is correctly installed. So we are going to type python/version. So as you can see all over here, we have successfully installed our Python. So guys, that was our prerequisite. Now, there are two ways to install Jupyter Notebook. The first one can be pip. Okay, pip is a package manager, or using Anaconda distribution. So let us see with pip first. So guys, pip is a package manager which is used to install and manage software packages, libraries written in Python. So you can see all over here that the Python with version greater than 3.6 have default pip installed in them. Okay, so we can use pip command to install our Jupyter Notebook. So guys, as you can see all over here, we have come to the official documentation of Jupyter.org, and it is saying that installing Jupyter Lab with pip command. So what you can do, guys, you can just copy all over here. You can go right all over here and click on this. Now, as you can see all over here, it has started downloading the Jupyter Lab. So guys, we are going to install our Jupyter Lab with the pip command. So this is the official documentation of Jupyter Notebook. Okay, and just all you have to do is copy this and type on your terminal. So as you can see all over here, it has started downloading the packages which is required to download the Jupyter Notebook. Let us wait for some time. Okay guys, so we have successfully completed this step. Now let us move on to our next step. So as you can see all over here, so we have installed, okay, then what we have to do, then you can type this, you can launch the Jupyter Lab with this command on the terminal. Now let us wait. So as you can see all over here guys, we have successfully installed our Jupyter Notebook. So you can go all over here and just create a new notebook, and you can also choose your kernel and you can start working on your Jupyter Notebook. Suppose I'll show you one snippet. So 3 plus 5, let us try to run this notebook. So as you can see, it is giving us the 8 as answer. So it is following the Python syntax, and in this way we have successfully installed our Jupyter Notebook using the pip command. So now, as you can also see all over here, you can also install Jupyter Notebook with this command, pip install notebook, and then you can just open it. This is also another alternative. Similarly, you can install with Viola also. Same command and just open the Viola. Now, if you are using any other operating system like macOS or Linux, then you can install by brew install Jupyter Lab. So Homebrew will be the package manager for macOS and Linux. So I hope so you are pretty clear with how to install Jupyter Notebook with the pip command. Now, I have downloaded Anacondas from this official website. So as you can see all over here, this is the official website of Anaconda. Okay. Now just type your email and you can just download it. So similarly, as you can see, after installing, I'm going to launch my installer and let us click next. Okay. Let us click agree. Okay. And let us install this on the given directory. Let us wait for some time till the installation gets complete. So guys, as you can see all over here, we have completed our installation of Anaconda. So just click on finish and you can say we have successfully installed our Anaconda. Now let us open our Anaconda navigator. So just click on So as you can see all over here, just right click on this and our Anaconda navigator will be opened. So as you can see all over here, this is our Anaconda navigator and it is loading the packages. And for us to install the Jupyter Notebook, so as you can see all over here, just click on launch. So guys, if you click on launch, it is going to open our Jupyter Notebook. So as you can see all over here, it is saying launching the Jupyter Notebook and it is hosted on localhost 8889. So this is our hosted Jupyter Notebook. And similarly, you can create a new notebook all over here. And in this way, you can start working.
And just like any modules, we have to import NumPy. We almost always import it as NP. That is such a standard. So you'll see that very commonly. We can just run that. And now we have access to our NumPy module inside our Python. And then the most common thing, of course, is to go ahead and create a NumPy array. And in here, we can send it a regular list. And so we'll go ahead and send this a regular array. Let's go 1, 2, 3 to make it simple. And then I'm just going to type in A, and we'll run this. And so you can see down here, the output is an array of 1, 2, 3. And we could also do print, just a reminder that this is an inline command, so that wouldn't work if you're using a different editor. You can see that it's an array 1, 2, 3. But we'll go ahead and leave it as A. Kind of a nice feature so you can see what you're doing really quick in the Jupyter Notebook. And just like all your other standard arrays, I can go a of 0, which is going to be a value of 1. Of course, we do a of 1. You go all the way through this. A of 1 has a value of 2 in it. So whether you're using the NumPy array or the basic Python list, that's going to be the same. That should all look pretty familiar and be pretty straightforward. Remember, the first value is always 0 and when we set on there. So let's take a look why we're using NumPy, because we went over the slide a little bit, but let's just take a look and see what that actually looks like. And what we want to look at is the fact that it's fast, convenient, and uses less memory. So let's take a glance at that in code and see what that actually looks like when we're writing it in Python and what the differences are. And to do this, I'm going to go ahead and import a couple other modules. We're going to import the time module so we can time it. And we're going to import the system module so that we can take a look at how much memory it uses. And we'll go ahead and just run those so those are imported. And so we'll do b equals range of 1. Yeah, 1,000 is fine. And so that's going to create a list of 1,000, 0 to 999. Remember, it starts at 0 and it stops right at the 1,000 without actually going to the 1,000. And let's go ahead and print. And we want system.getSize of. And we'll pick any integer because we have, 0 to 1,000. We'll just throw one in there, 5. It doesn't matter because it's going to, whatever integer we put in there is going to generate the same value because we're looking at the size of how much memory it stores an integer in. And then we want to have the length of the b. That's how many integers are in there. And if we go ahead and execute this and run this at a line, we'll see, oops, I did that wrong, comma. If we multiply them together, we'll see it generates 28,000. So that's the size we're looking at, is 28,000. I believe that's bytes. That sounds about right. So let's go ahead and create this in NumPy. And we'll go with c equals np. And this is a range. So that's the NumPy command to do the same thing that we were just doing in a list. And we'll also use the same value on there, the 1,000. And then once we've created the value of c for np.arange, let's go ahead and print. And we can do that by doing c.size times c.item size. And that's very similar to what we did before. We did get the size of, so the c size is the size of the array, and each item size, just reversed. So it's the size of an integer 5, item size is going to be the integers, and c size. And let's just take a look and see what that generates. And wow, okay, we got 4,000 versus 28,000. That's a significant difference in memory, how much memory we're using with the array. And then let's go ahead and take a look at speed. Let's do size. We tried this with lower values, and it would happen so fast that the NP array kept coming up with 0 because it just rounded it off. So size, and let's create an L1 equals range of size, and we'll do an L2. We'll just set up to the same thing. It's also range of size on there. There we go. And then we can do on A1 equals np dot arange size. And then let's do on A2 equals np dot arange. We'll keep it the same size. And what we're going to do is we're going to take these two different arrays and we're going to perform some basic functions on them. But let's go ahead, actually let's just load these up now. We'll go ahead and run this so those are all set in memory. Except for the typo here. Quickly fix that. There we go. So these are now all loaded in here. And let's do a start equals time.time. So it's just going to look at my clock time and see what time it is. And then we'll do result equals, and let's do, let's say we got an array, and we're going to say, let's do some addition here. X plus Y for X comma Y. And we'll zip it up here. Two different arrays. So here's our two different arrays. We're going to multiply each of the individual things on here. L1, L2. There we go. So that should add up each value. So L1 plus L2, each value in each array. And then we want to go ahead and print, and let's say Python list took, and then we'll do time dot time. We'll just subtract the start out of there. So time, whoops, I messed up on some of the quotation marks on there. Okay, there we go. Time minus the start. And we'll convert that to seconds. So we'll go, because that's in milliseconds, so times 1000. And let's hit the run on there. This is kind of fun because you also get a view while we're doing this of some ways to manipulate the script. And as you can see, also my bad typing. There we go. Okay, so we'll go ahead and run this. And we can see here that the Python list took 34. Actually, I have to go back and look at the conversion on there. But you can see it takes roughly 0.34 of a second. And we can go ahead and print the result in here too. Let's do that. And we'll run that just so you can see what kind of data we're looking at. And we have the 0, 2, 4, 6, 8. So it's just adding them together. It looks pretty straightforward on there. And if we scroll down to the bottom of the answer, again, we see Python list took 46. A little different time on there depending on what core, because this is on an 8-core computer, so it just depends on what core it's running on, what else is pulling on the computer at the time. And let's go back up here and do our start time. Paste that into here. And this time we're going to do a result equals, and this is really cool. Notice how elegant this is. It's so straightforward. This is a lot of reason people started using NumPy is because I can add the two arrays together by simply going A1 plus A2. It makes a lot of sense, both looking at it, and it's just very convenient. Remember that slide we're looking at? Fast, convenient, and less memory. So look how convenient that is. Real easy to read, real easy to see. And I don't know if we don't need to print the result again, so let's just go ahead and print the time on here. And we'll borrow this from the top part because I really am a lazy typer. And this isn't the Python list, this is the NumPy list, or NumPy array. And let's go ahead and see how that comes out. And we get 2.99. So let's take a look at these two numbers, 46 versus 2.99. So we'll just round this up to 3. That's a huge difference. That's like more than 10 times faster. That's like 15 times roughly at a quick glance. I'd have to go do the math to look at it. And it's going to vary a little bit depending on what's running in the background on the computer, obviously. So we've looked at this, and if we go back here, we found out it's much faster. Yes, there's going to be different speeds depending on what you're doing with the array. Very convenient, easy to read, and it uses less memory. So that's the core of the NumPy. That's why a lot of people base so many other modules on NumPy and why it's so widely used. So we did glance at a couple operations while we were looking at speed and size. Let's dive into a little bit more into the basic operations. And these are always nice to see. I mean, certainly you want to go get a cheat sheet if you're using it for the first time. Look things up. Google is your friend. We did this for the most basic numpy.array or np.array. And we'll go ahead and create an array. Let's do pairs, 1, 2. And then let's do 3, 4. And if we're going to do that, let's do 5, 6. There we go. And if we go ahead and take this and run this, I can go ahead and do our A down here so it's in line and it'll print that out. You can see it makes a nice array for us. So we have A, and if you look at that, we have 3 different objects, each with 2 values in them. And hopefully you're starting to think, well, how many dimensions or indexes is that? And you'll see 3 by 2. So let's go ahead and take a look, and let's go, how about A.nDimensions? Speaking of which, we'll run that, and we have 2 dimensions for each object. And then we can do the item size, so A dot. We saw this earlier, where we looked up how many items. It was up here, where we wanted to multiply item size times the actual size of the object. So the memory is being used versus the item size. And we should see 4 there. Memory is compressed down. That's always a good thing. And then the shape. The shape is so important when you're working with data science and you're moving it from one format to another. So we have our shape. We just talked about that. We have 3 by 2. 3 rows by 2 objects in each one. Generally, I don't look too much at the size, but the dimensions I'm always looking up. And this is nice, you can automate it. So you might be converting something, you might need to know how many dimensions are going into the next machine learning package so that you can automatically just have it send that information over. So we looked at a shape. Let's go ahead and create a slightly different array, np.array. Let's go ahead and just do as our original setup here. And one of the features we can do, which is really important, is we can do dtype equals. In this case, let's do np float 64. And so what we've done is we're converting all of these into a float, and we type in A. And now instead of having 1, 2, 3, 4, 5, 6, you see they're all float values. 1.0, there's no actual 0 in there, just there's a 1 dot, or the 1 period, 2, 3 period, 4 period, 5 period, 6 period. And this, again, data science, I don't know how many times I've had to convert something from an integer to a float so this is going to work correctly in the model I'm using. So very common features to be aware of and to be able to get around and use. And we'll also do, let's just curiosity, item size. We'll go ahead and run that. And we see that it doubled in size. So it's not a huge increase. Well, doubling is always a big increase in computers. But it's not a huge increase compared to what it would be if you're running this in the Python list format. And then we did the shape earlier without having it set to the float 64. Let's go ahead and do a shape with it set to 64. And it should be the same 3, 2. So it all matches. So we've gone through, and remember, if this is all brand new to you, according to the Cambridge study at the Cambridge University, if you're learning a brand new word in a foreign language, the average person has to repeat it 163 times before it's memorized. So a lot of this, you build off of it, so hopefully you don't have to repeat it 163 times. But we did manage to repeat it at least twice here, if not a little bit more. And let's go ahead and take this. We're going to go look at one more setup on here. And let me just take this last statement here on the converting our properties of our data. And instead of float 64, let's do complex. Let's just see what that looks like. And let's go ahead and print that out and run it. And so we now have a complex data set up, and you'll see it's denoted by the 1 dot plus 0 dot j. And if we flip over here and do a basic search for NumPy data types, better to go to the original web page, but pull up a bunch of these. You can see there's a whole list of different NumPy data types. Shorthand, complex, we have complex, complex 64, complex 128. Complex number represented by 2 64-bit floats, real and imaginary components. One option on there, float 16, float 32. Float, shorthand for float 64, most commonly used. And of course all the different ones that you can possibly put into your NumPy array. So we covered a basic addition up there when we were comparing how fast it runs. But some very basic components, how to set up a NumPy array, how many dimensions it has, item size, data type, again we went to item size, and there's also the shape, probably one of the more used. I use a shape all the time, very commonly used. And then down here you can see where we actually created a NumPy complex data type. So let's look at some other features in NumPy. One of them is you could do NumPy dot zeros, and we're going to do 3, 4. There we go. And we'll go ahead and run this, and you can see if I do np.zeros, I create a NumPy array of zeros. This is really important. I was building my own neural network, and I needed to create an array where I initialized the weights, and I wanted them all to be the same weight. In this case, I wanted them to start off as 0 for the particular project I was working on. And there's other options, like you can do NumPy1s, and we'll do the same thing, 3, 4, we'll run that. And you can see I've created an array of NumPy1s. In this case, it comes out as a float array. And then this is an interesting to note, because we have, let's go back to our Python and do L range 5, and we'll print the L, so there's our list. And if I run that, it doesn't create the range until after the fact, until you actually execute it. That's an upgrade in Python. Python 2.7 actually created the array 0, 1, 2, 3, 4. This one actually creates the script, and then once it's used, it then actually generates the array. And if we do that in numpy A range, remember that from before, and if we do numpy A range 5, and let's do L equals, or we can just leave it as numpy, that's fine. There we go, just run that. You can see there we actually get an array, 0, 1, 2, 3, 4 for the value of the numpy A range 5. It generates the actual array. And for part 1, we're going to do just one more section on basic setup, and we're going to concatenation, do a concatenation out example. There we go. We're going to do strings. Let's take a look at strings and what's going on with there. And let's do, let's see, print. Let's do an NP character, something new here. And we're going to add, and then here's our brackets for what we're going to add. And let's say, let's do hello, comma, hi. And in the brackets on there, let's create another one. And this one's going to be ABC, and we'll do XYZ. So we're just creating some, randomly making some up on here. And then we'll go ahead and just print this. If we run that, you can come down here, and of course make sure all your brackets are open and closed correctly. And then you can see in here when we concatenate the example in NumPy, it takes the two different arrays that we set up in there, and it combines the hello with the ABC and the hi with XYZ. And if we can also do something like print, let's do np character dot multiply. So there's a lot of different functions in here. Again, you can look these up. It's probably good to look them all up and see what they are, but it's good to also just see them in action. And let's do hello space, comma, 3. And we'll run this one and run that without the error. And you'll see it does hello, hello, hello. So we multiplied it by 3. And we can also, and let's just take this whole thing here instead of retyping it. And we can do character center. So instead of multiply, let's do center. And over here, keep our hello going. Take the space out of there. And let's do center at 20 and fill character equals, we'll fill it with dashes. So if we run this, you can see it prints out the hello with dashes on each side. And we keep going with that. We can also, in addition to doing the fill function, we can play with capitalize, we can title, we can do lowercase, we can do uppercase, we can split, split line, strip, join. These are all the most common ones. And let's go ahead and just look at those and see what those look like, each one of them. Here we're going to do the hello world, all-time favorite of mine. I always like to say hello universe. And you can see here we did a capital H with the world, but so we want to capitalize. So capitalize is the first one in the array. So we get hello world on there. And we can also take this, and instead of capitalizing, another feature in here is title. And let's just change this to how are we doing? How are you doing? Instead of we, we'll do you. And let's run that. And you can see here, because we created it as a title, it capitalizes the first letter in each word. And in this one, we're going to do character lower. Two different examples here. We have an array. We have hello world all capitalized, and we have just hello. And you can see that one is an array and one is just a string. If we run that, you get an array with hello world lowercase and hello lowercase. And if we're going to do it that way, we can also do it the opposite way. There's also upper. And let's paste those in there. And you can see here we have character.upper, opposite there, python.data, and we'll do Python is easy. Hopefully you're starting to get the picture that most of the Python and the scripting is very simple. It's when you put the bigger picture together and starts building these puzzles, and somebody asks you, hey, I need the first letter capitalized, unless it's the title, and then you start realizing that this can get really complicated. So NumPy just makes it simple, and we like that. And so in this case, we did Python data. It's all uppercase. Python is easy, like shouting in your messenger. Python is easy. And then if you're ever processing text and tokenizing it, a lot of times the first thing you do is we just split the text, and we're just going to run this np.character.split. Are you coming to the party? If we do that, it returns an array of each of the individual words. Are you coming to the party, splitting it by the spaces? And then if you're going to split it by spaces, we also need to know how to split it by lines. And just like we have the basic split command, we also have split lines. Hello, and you'll see here the scoop in for our new line. And when we run that, if you're following the split part with the words, you should see hello, how are you doing? The two different lines are now split apart. And let's just review 3 more before we wrap this up. Commonly used string variable manipulations. We have strip, and in this case we have Nina, admin, Anita, and we're going to strip A off of there. And let's see what that looks like. And then you end up with nin, demin, nate. It basically takes up all leading and trailing letters. In this case we're looking for A. More common would be a space in there, but it might also be punctuation or anything like that that you need to remove from your letters and words. And if we're going to strip and clean data, we also need to be able to reformat it or join it together. So you see here we have a character join. We'll go ahead and run this. And it has on the first one, it splits each of the letters up by the colon and the second one by the dash. And you can see how this is really useful if you're processing, in this case, a date. We have day, month, year, year, month, date. Very common things to have to always switch around and manipulate depending on what they're going into and what you're working with. And finally, let's look at one last character string. We're going to do replace. If you're doing misinformation, this is good, pulling news articles and replacing is and what. In this case, we're just doing he is a good dancer. We're going to replace is with was. And you can see here, he was a good dancer. Hopefully that's not because he had a bad fall. He just was from 1920s and has gotten old. So there we go. We've covered a lot of the basics in NumPy as far as creating an array. Very important stuff here when you're feeding it in. How do we know the shape of it, the size of it? What happens when we convert it from a regular integer into a float value as far as how much space it takes? We saw that that doubled it. Item size, you have your in dimensions, and probably the most used is shape. And we'll cover more on shape in part 2. So make sure you join us on part 2 because there's a lot of important things on shape in there and setting them up. We also saw that you can create a zeros-based array. You can create one with ones. If we do a range, you can see how it is a lot easier to use to create its own range, or a range as it is in NumPy. And you saw how easy it was to add 2 arrays. We saw that earlier, just plus sign. Then we got into doing strings and working with strings and how to concatenate. So if you have 2 different arrays of strings, you can bring them together. We also saw how you can fill, so you can add a nice headline, dash, dash, dash. We saw about capitalize the first letter. We saw about turning it into a title, so all the first letters are capitalized. Doing lowercase on all the letters, upper for all the letters, just lower and upper, nice abbreviation. We also covered how to split the character set, how to strip it. So if you want to strip all the A's out from leading A's and ending A's or spaces, you can do that very easily. Also, how to join the data sets. So here's a character join option for your strings. And finally, we did the character replace. Now let's go ahead and dive in there since we're going right into part 2, which is getting some coding going under our belt. And here in our Jupyter notebook, we can go under new and create a new folder, Python 3. I think I forgot to do this last time, but we could just do the Control++, which in any browser enlarges a page, makes it a lot easier to see. Always a nice feature. Another beautiful benefit of using Jupyter Notebook. And let me go ahead and show you a neat thing we can do in Jupyter. This is nice if you're working with people and you're doing this as a demo on a large screen. I'm going to do the hashtag or pound symbol array manipulation, kind of a title of what we're working on. And then I'm going to call this cell type markdown as opposed to code. And you'll see it highlights it here, and then if I run it, it just turns it into array manipulation. And then we're specifically going to be working on array manipulation, changing shape to start with. And we'll go ahead and mark this cell also a markdown, so it has a nice little look there. And then it comes up, and you can see it, just like I said, it just highlights it and makes it in bold print, just making it easier to read. Not a Python thing, but a Jupyter thing that's good to know about, especially if you're working with the shareholders, since they're investing money in you. Of course, the first thing we do is import. We're going to import NumPy as in P, and that should be standard by now. By now, you start a Python program, you're doing some data science. NumPy is just something you bring in there. And let's go ahead and create our array. And we're going to do that as the np.arange. Remember, that's 0, well, we're going to do 0 to 9. And then we'll go print, put a little title on the original array. We'll just print that array A. Remember from the first lesson, so we have our array which is 0, 1, 2, 3, 4, 5, 6, 7, 8. And let's add a print space in between. Let's create a second array, B, but we want this to reshape array A. And what does that mean? And the command is simply reshape. And then we have 9 items in here, and this is so important right now. So be very aware, if I did some weird numbers in here, it's not going to work. And we want multiples of 9. We know that 3 times 3 is 9. So we're going to reshape our A array by 3 by 3. And then we're going to print, well, let's give it a title. Oops, I had too many brackets in there. Modified array, and then let's go ahead and print our B. And let's see what that looks like. And as we come down here, you can see we've taken this and it's gone from 0, 1, 2, 3, 4, 5, 6, 7, 8 to an array of arrays. And we have 0, 1, 2, 3, 4, 5, 6, 7, 8. And so we split this into 3 by 3. And you can guess that if I tried to reshape this, let's just do a 5 by 3, which is 15, that's going to give me an error. So it's not going to work. You're not going to be able to reshape something unless the shape, all the data in there matches correctly. So we can take this flat 9, and we call it a flat because it's just a single array. And we can reshape it into a 3 by 3 array. And first you might think matrices, which this is used for that, definitely. I use it a lot in graphing because it'll come in that I have an array that's xy, comma xy1, y1, comma x2, y2. And so the shape of it might be 2 by the length of the number of points. And I need to separate that into x flat array and a y flat array. And you can see this can be very easy to reshape the array doing that. And we can of course go back. We can do B, do a print, and we'll do B dot flatten. Remember I said it's called a flatten array? And if we run that, you'll see it just goes back to the original one. It takes this 0, 1, 2, 3, 4, 5, 6, 7, 8 and flattens it back to a single array. And then one other feature to be aware of is if we flatten it, one of the commands we can put in there is order. Let me just go ahead and do that. Order equals F. Strangely enough, F stands for Fortran. The whole Fortran days, I remember actually studying Fortran programming language. In this case, you'll see that it uses the first, like 036 is the order. So instead of flattening it like we had before, 0, 1, 2, 3, 4, 5, 6, 7, 8, it now does 0, 3, 6, 1, 4, 7, 2, 5, 8. And if you go to the NumPy array page, you can see here that they have the flatten. I just open up the NumPy ND array flatten setup to look it up. And they have 3 different options. They have C, F, and A. And it's whether to flatten in C, which was based on how the C code works for flattening, originally worked, which is row major, Fortran, which is column major, or preserve the column Fortran ordering from A. So whatever it was in, the default is the C version. So the default that you saw, you could put order equals C and it'd have the same effect as we saw there before. You could even do order equals A. That would also have the same effect because that's the default. So really the only other thing you really should change on here is to change it to C if you need it. And you can see right here, or F, I mean not C. The only thing you really want to change it to is to your F for the Fortran order, which then does it by column versus by row. And let's look at, here we go, reshape. So let's create a range of 12, and let's reshape it. And we'll do 4, 3 for this one. And remember this is NumPy. I forgot the NP there. np.arrange. And we can type in just A for print, or you can do full print A. And of course, the Jupyter Notebook even have a little extra print at the beginning. When we run this, we'll see we create a nice array of 0, 1, 2. It's reshaped it. So we have 4 rows and 3 columns, or you could call that 3 columns and 4 rows. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. But this one is so important. We'll do np transpose A. Let's go ahead and run that. And it helps if I get all the S's in there and don't leave an S out. And you'll see here we've taken our array. If you remember correctly, we had 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. and we've swapped it. So we've gone from a 3x4 or a 4x3 to a 3x4. And this really helps if you're looking at like a huge number of rows and the data all comes in. Like let's say this is your features in row 1, your features in row 2, and this is XYZ. Well, when you go to plot it, you send it all of X in one array, all of Y in one array, and all of Z in another array. And so it's really important that we can transpose this rather quickly. This is kind of a fun thing. I can highlight it and do brackets around it, and if you remember correctly, because we're in Jupyter, it doesn't matter where we do the print or not. It'll automatically print it for us. And you see if I hit the run button, it comes up with the same exact thing. And let's play with the reshape, and you know what, let's zoom this up a little bit here. Make that even bigger so you can really see what's going on. And let's play with the reshape just a little bit more. We'll do b equals np.arange. Let's do 8. And reshape, we'll do 2, 4. Let's go ahead and print B and then run that. And you'll see we have now the 2 rows. This is a bit more like, so we have 4, maybe 2 rows of 4 things. So this might be all of our X components and our Y components. So we can switch it back and forth real easy. Important to note here, whether we do 2, 4, or in the case of 4, 3, this has 12 elements. And so however you split it up, it's got to equal 12. So 4 times 3 equals 12. That's pretty straightforward. Same thing down here. 2 times 4 equals 8. If I change this, and let's say I do 2, 3, let's just run that in, and you'll find we get an error because you can't split 8 up into 2 rows by 3. You have to pick something that it can split up and arrange it in. So let's go ahead and run that. And just for fun, let's go reshape our B again, if I can type. Reshape our B again. And what else goes into 8? Well, we could do 2 by 2 by 2. So we can take this out to 3 different dimensions. And then if we, because this is going to come out as a variable, we can just go ahead and run it. And it'll print it. We could also do a print statement on there, just like we did before. And you'll see we have 2 different groups of 2 variables of 2 different dimensions. So 2 by 2 by 2. And let's go ahead and assign this to a variable. C equals B reshape. And let's do something a little different. Let's roll the axes. Roll axes. And we'll take our C and do 2, 1. And if we go ahead and run this, it's going to print that out. Whoops. Hit a wrong button there. Let's do that one again. And you roll the axis, and you can see that we now have, instead of 0, 1, 2, 3, 4, 5, 6, 7, we now have the 0, 2, 1, 3, 4, 6, 5, 7. So what's going on here? We're taking and we're rolling the numbers around, and let's just simplify this. We'll just do it with C, 1 and run that. And so if we roll a single axis, you got 0, 1, and then it rolled the 4, 5 up, and then we have 2, 3, 6, 7. And if we do 2, let me see what happens there. And this is one of those things you really have to play with and start feeling what it's doing. We've now taken 0, 2, 4, 6, 1, 3, 5, 7. So you can see we've now rolled by 2 digits. Instead of rolling the 1 setup, we now rolled 2 digits up there. And so if we go back and we do the 1, so we've rolled it up, 0, 1, 4, 5. And then we're going to take the 2 in there. And we've rolled the 0, 1, 2, 3, 4, 5, and 6, 7. So we start rolling these things around on here. There's a lot of different things you can do on this. But it's another way to manipulate the numbers on your NumPy. And finally, let's go ahead and swap axes. We'll do C. And let's just go ahead and run that. It's going to give me an error on there. That's because it requires multiple arguments. Left out the arguments. So now we can swap them. We get the 0, 2, 1, 3, 4, 6, 5, 7. So you can see everything's been swapped around. So next thing we want to go over is we want to go over NumPy arithmetic operations. How can we take these and use these? Let me just go ahead and put this cell as a markdown. There we go. We'll run that so it has a nice thing. All right, nice title on there. That's always helpful. And let's start by creating 2 arrays. We'll do A is an NP range, A range 9. And let's reshape this 3 by 3. So by now you should be seeing this reshape stuff, and this should all look pretty familiar. We have our 0, 1, 2, 3, 4, 5, 6, 7, 8 on there. And let's create a second one, B. And this time, instead of doing A range, let's do NP array. We'll just create a straight up array. And we'll do an array of 3 objects. So it's going to be 3 by 1. And if we go ahead and print B out, we run that. This is actually pretty common to have something like this, where you have a 3 by whatever it is and a 3 by 3 array. When you're doing your math, you kind of have that kind of setup on there. And what we can do is we can go np.add AB. Don't forget, we can always put a print statement on there. So if we add it, you'll see that it just comes in there and it goes, okay, we're adding 10 to everything. And we could actually do something more, make it more interesting. 11, 10, 11, 12. So let's change B's now, 10, 11, 12, and let's run that. And you can see that we have 10, and then you had 1, plus 11 is 12, 2 plus 12 is 14, 13, so 10 plus 3 is 13, 11 plus 4 is 15, and 12 plus 5 is 17, and so on. We'll put this back, since that's how the original setup was. Let's do 10 by 10 by 10, and run that, and get the original answer. And if you're going to add them together, we need to go ahead and subtract AB, and we run that. We get minus 10, minus 9, minus 8, just like you would expect. So we have our subtraction. 0 minus 10 is minus 10, and so on. And if you're going to add and subtract, you can guess what the next one is. We're going to multiply. And we'll multiply AB. And this should be pretty straightforward. You should expect this. If we multiply 10 times 0, we got 0. 10 times 10 is 10, and so on. And finally, if you're going to multiply, what's the last one we got is divide. What happens when we do divide A by B? And we run this, and we're going to get 0. And this is 0 divided by 10 is 0, 1 divided by 10 is 0.1, 2 divided by 10 is 0.2, and so on and so on. So the math is pretty straightforward. It just makes it very easy to do the whole setup. And again, if we went this, and let's say, let's change this up here. Instead of 10, we do 100. And make this 1,000. There we go. And if we run that, and then we do the add, you can see we got 10 plus 100 plus 1,000. Same thing with the subtract. Same thing with the multiply. And then you can also see the same thing here with the divide. So a lot of control there with your array and your math. Again, let's set this back to 10. Oops, it's right up here, wrong section. There we go, 10. And we'll just go ahead and run these and get back to where we were. And this brings us to our next section, which is slicing. And let's put in our, we'll just make this a cell type markdown. And then we run that. Of course, it gives us a nice looking slicing there. And the slicing means we're just going to take sections of the array. So let's create an array NP A range. Let's just do 20. And if you remember, if we do A, we have a 0 to 19. And then we can do A, and remember we can always print these. This can always be put in a print, but because I'm in Jupyter, if you're doing a demo in Jupyter, it's just so great that you have all these controls on here. So we can slice 4 on, and this should look familiar because this is the same as a Python and a lot of other different scripting languages. If we do 4, it goes 0, 1, 2, 3, that's the first 4 in the thing, and it skips some and starts with this one. The first 4 are skipped, and then from there on. You can also do the opposite and go till the 4th one. If we run that, we get 0, 1, 2, 3. Quite the opposite on there. We can do a single item, so we can pick object number 5 on the list, run that, and 5 happens to be 5, because that's the order they're in. And then this one's interesting, because I can do s equals slice, and let's create a slice here, and let's do 2, 9, let's leave it 2 on there. So we'll create an S slice on here. And then if we take our array and we do array of S, we're taking our slice in there, and let's go ahead and run that. And let's take a look and see what it generated here. First off, we started with 2, so we have 2 at the beginning. We're going to end at 9, which happens to be 8, so it stops before the 9. Remember when we're doing arrays in Python. And then we step 2, so 2, 4, 6, 8. We could do this as 3. Let me run that, and you can see how that changes, 2, 5, 8. And we could do this as, let's leave this at 3, and if we change this to 10, oops, let's make it 12. There we go. And we run that, we have 2, 5, 8, 11. So that's pretty straightforward, but it's a very nice feature to have on here where you can slice it and take different parts of the series right out of the middle. So now that we've access to different pieces of our array, let's get into iteration. And this is interesting because my sister, who runs a college data science division, the first question she asks is, how do you go through data? And she's asking, do you know how to iterate through data? Do you know how to do a basic for loop? Do you know how to go through each piece of the data? And in NumPy, they have some cool controls for that. So put this in as a markdown. There we go, and run it. And it's called the ND-iter. I'm not sure what the ND stands for, but ND-iter for iterator. So before we do that, though, let's create an array or something we can actually iterate through. We'll call it A equals NP A range. Let's do something a little funny here, or funky. And we'll do 0, 45, 5. I'm not sure why the guys in the back picked this particular one, but it's kind of a fun one. And if I run that, we do this, you can see we get 0, 5, 10, 15, 20, 25, 30, 35, 40. That's what this array looks like. And that's just from our slice. This is just a slice. That's all that is we created a slice of 0 to 45, step 5. And so we can do with this, we can also do A equals reshape. Let's go ahead and take and reshape this. And since there's 9 variables in there, we'll do a reshape at 3 by 3. So if we run that, whoops, missed something there. That is the A. That really helps. So if we do the A reshape, and we'll go ahead and print that out, we get 0, 5, 10, 15, 20, 25, 30, 35, 40. And then we simply do 4xn, our NumPy ND-iter of A, colon, and we'll just go ahead and print x. And let's see what happens here when we run through this and we print each one of those. It goes all the way through the whole array, so it's the same thing we just saw before. We got 0, 5, 10, 15, 20, 25, 30, 35, 40. So it prints out each object in the array, so you can go through and view each one of these. And certainly if you remember, you could also flatten the array and just do for A and that also and get the same result. There's a lot of ways to do this, but this is the proper way with the ND iterator because it'll minimize the amount of resources needed to go through each of the different objects in the NumPy array. And hopefully you asked this question when I just did that. And the question is, how can I change this instead of doing each object? So first of all, let's go ahead and take my cell type, and we're going to mark that down and run it. And so we're going to work on iteration order C style and F style. Remember C because it came from the C programming, and F because it came from the old Fortran programming. So let's give us a reminder. We'll do a print A, and we'll do 4xn np iterate A. But we also want to do this in a specific order. And you know what? I'm a really lazy typer, so let's go back up here. This is the ND iterator. I knew I was missing the ND part of A. And let's do order equals C. We'll print X on there. And let's do that again. And this time order equals F. There we go. Order equals F. And let's go ahead and run this and see what happens here. And the first thing you're going to notice, our original array, 0, 5, 10, 15, 20, 25, 30, 35, 40. When we do order C, that's the default, 0, 5, 10, 15, 20, and so on. And then when you come down here, you'll see F, order F, is 0, 15, 30. So it takes the first digit of each of the subarrays, or the second dimension, and then it goes into the second one, 5, 20, 35, 10, 25, 40. So slightly different order for iterating through it if you need to do that. So we've covered reshaping, we've covered math, we've covered iteration, we've covered a number of things. The next section we want to go ahead and go over is going to be joining arrays. So we need to bring them together. Let me go ahead and take the cell and make it a markdown. Cell type Markdown. There we go. And run that. So let's work on joining arrays so we can bring them together and what different options we have. And let's do, we'll do an NP array 1, 2, 3, 4. We'll go ahead and print. Let's do, oops, first. Well, these arrays aren't that big, so let's just go ahead and keep it all on one line, A. So if we run this, first array 1, 2, 3, 4. Whoops, I forgot that it automatically wraps it when you do it this way. So we'll go ahead and keep it separate and print A. There we go. And let's go ahead and do a B. And we'll do 5, 6, 7, 8. And notice I'm keeping the same shape on these two arrays. Depending on what you're doing, those shapes have to match. And let's go ahead and print second array. Do a print B. We'll go ahead and run that. Oops. Messed something up there. Let me fix that real quick. When I was reformatting it to go on separate lines, I messed that up. There we go, run. All right, so we have first array 1, 2, 3, 4, second array 5, 6, 7, 8. And we'll put a carried return on there. And the key word we use is concatenate. And if you're familiar with Linux, it usually means you're adding it to the end on there. And we're going to do what they call along axis 0. So we have concatenate AB along axis 0. Let's go ahead and run that and see what that looks like. And so we have 1, 2, 3, 4, 5, 6, 7, 8. So now we have an array that is 4 by 2. Has a nice shape of 4 by 2 on here. And if we're going to do it along the axis 0, you should guess what the next one is. We're going to do it along the 1 axis. And let's see how those differ from each other. Let's just go ahead and run that. And again, all we're doing is adding in the axis equals 1. So we have our concatenate, we have AB, and then axis 1. Remember a couple things. One, these are the same shape. So we have a 2 by 2, same dimensions going in there. You're going to get an error if you're concatenating and they're not. If you have something that instead of 1, 2 is 1, 2, 3, 4, 5, 6 with a 5, 6, 7, 8. They'll give you an error on there. In fact, let's take a look and see what happens when we do that. Let me just take this. 1, 2, 3, 3, 4, 5. And let's run that. And if we come down here, we got there. It says all the input array dimensions except for the concatenation axes M must match exactly. So it'll let you know if you mess up. That's always a good thing. Let's go ahead and take this back here, and let's go ahead and run that. And so we have our 0 axes, which is 1, 2, 3, 4, 5, 6, 7, 8. And we bring them together. And you'll see a very different setup here when we do it along the axis 1. We end up with, instead of 4 by 2, we end up with a 2 by 4. 1, 2, 5, 6, 3, 4, 7, 8. And that's just changing which axes we're going to go ahead and concatenate on. What I find is when you're talking about the concatenate or the joining arrays, you really got to play with these for a while to make sure you understand what you mean by the axes. It looks very intuitive when you're looking at it. Axis 0, 1, 2, 3, 4, 5, 6, 7, 8. Axis 1 is then splitting it a different way, 1, 2, 5, 6, 3, 4, 7, 8. When you're actually using real data, you start to really get a feel for what this means and what this does. So if we're going to do that, let's go ahead and look at splitting the array. And do that under Markdown and run it. There we go. So you have a nice little title there. And we'll go ahead and create an array of 9. Let's do NP split. We'll do A, and we're going to split it by 3. Let's just see what that looks like. So if we split it, we get an array 0, 1, 2, 3, 4, 5. We get 3 separate arrays on here. Now remember, we're looking at, let me just print A up here. So we're looking at 0, 1, 2, 3, 4, 5, 6, 7, 8, and then we can split it into 3 separate arrays. And let's take this, we're going to do this right down here, just move the A split down here. Instead of the 3, let's do 4, 5, and put that in brackets. And so when we do it this way, we have 0, 1, 2, 3, 4, 5, 6, 7, 8. And that's kind of interesting. I wasn't sure what to expect on that, but we get, when you split it A by 4, 5, you get a totally different setup on here as far as the way it split the array. And to understand how this works, I'm going to change the 5 to a 7. And this will visually make this a little bit more clear. So we had 4 and 5, it went 0, 1, 2, 3, 4, 5, 6, 7, 8. And you see the markers 4 and 5. When we do 4 and 7, I get 0, 1, 2, 3, 4, 5, 6, 7, 8. And so what you're looking at here is the first markers, this is going to go to 4. So there's our first split at the 4, the marker at 4, and then the second split is going to be at position 7. And this is the same thing here. 4, position 5. That's why we're splitting it in those two sections. We could also do it 7, just to see what that looks like. Run. And you can see I now have 0, 1, 2, 3, 4, 5, 6, 7, 8. So we can split it in all kinds of different ways and create a different set of multiple arrays on here and split it all kinds of different ways. And before we get into the graphs and other miscellaneous stuff, let's go ahead and look at resizing the array. We'll go ahead and take this cell and set the cell as a markdown and run it. Give us a nice title there. And we'll do an array, an NP array of 1, 2, 3, and 4, 5, 6 here. And let's go ahead and just print. Let's go print a dot shape. And we'll go ahead and run that. Whoops, hit a wrong button there. Hit the comma instead of the dot. So we have a shape of 2, 3 here. And this is important to note because when we start resizing it, it's going to mess with different aspects of the shape. And so we'll go ahead and do a print. Scoop in for a blank line. There we go. Now let's do b equals np dot resize. We're going to resize A, and let's resize it with 3 by 2. And then we'll just go ahead and print B and print B period shape, not a comma. We'll run that. Oops, forgot the quotation marks around the end. We'll go ahead and run that, and let's just see what that looks like. So we have 1, 2, 3, 4, 5, 6, our original array, with a shape of 2, 3. And then we want to go ahead and resize it by 3, 2. And we end up with 1, 2, 3, 4, 5, 6, and we end up with the shape of 3, 2. That shouldn't be too much of a surprise. You know, we got 6 elements in there. We can resize it by 2, 3 was the original one, and then we're actually just reshaping it is how that kind of comes out as when you resize it like that. But what happens if we do something a little different? And let's go ahead and just take this whole thing and copy it down here so we can see what that looks like. And instead of doing 3, 2, remember last time I did the, to reshape it, I messed with the numbers and it gave me an error. Well, when you resize it, you don't have to match the numbers. They don't have to be the same dimensions. So we can, instead of going from a 2, 3 to a 3, 2, we can resize it to a 3, 3. So let's take a look and see how it handles that. And when we come down here to 3, 3, we end up with 1, 2, 3, 4, 5, 6, and it repeats 1, 2, 3. So it actually takes the data and just adds a whole other block in there based on the original data and repeating it. All right, now at this point, we've been looking at tons of numbers and moving stuff around. What we want to go ahead and do is get a little visual here because it certainly you can picture all the different numbers on there, but let's look at histogram. Let's put this into a histogram. Let me go ahead and run that. And to do that, we're going to use the matplot library. So from matplot library, we're going to import pyplot as PLT. And that's usually the notation you see for pyplot. So if you ever see PLT in a code, it's probably pyplot in the matplot library. And then the guys in the back did a nice job, and gals too, guys and gals back there. Our team over at Simplilearn put together a nice array for me, 20, 87, 4, 40, 53, with a bunch of numbers. That way we had something to play with. And what we want to do is we want to do plot the histogram. Now remember, a histogram says how many times different numbers come in. And then we're going to put them in bins. And we have bins 0 to 20 to 40 to 60 to 80 to 100. You might, in here with the matplot library, they call them bins. You might hear the term buckets, or they put them in buckets. That's a really common term. Then we want to give it a title. So The way it works is you do your plt.hist for histogram, your plt title, and your plt show, and we're doing just a single array in here in the numpy array of A. And let's go ahead and run this piece of code. Take it a moment to come out there, so it's figure size, so it's generating the graph. And you can see we have, and let's just take a look at this. Let me go down a size. There we go. Okay, so now we can see what we're taking a look at here. So between 0 and 20, we have 3 values. So we have a 20 here, we have a 4, and a 11, and a 15. 0, 1, 2, 3. It's actually 4 values, but they start at 0. So remember, we always count from 0 up. And from 20 to 40, we got 20. So it's 1, 42, 3, 4, 5, 6. And so you can see in the histogram, it shows that the most common numbers coming up is going to be between the 40 and 60 range, least common between the 80 and 100. This looks like an age demographics, is what this looks like to me. And you can see where they would have put it in the buckets of different age groups, which would be a nice way of looking at this. Histograms are so important and so powerful when you're doing demos and explaining your data. So being able to quickly put a histogram up that shows what's common and how it's trending is really important. And using that with a numpy is really easy. And you know what, let's take the same data, and I want to show you why we do bins, or why we have buckets of data. I'm used to calling it buckets. Why we have bins. Let's do it instead of by 20, let's do it by tens and see what happens. And what happens when you do it by tens is you miss out on you can see a nice curve here on the first one, and on the second one it looks like a ladder going up and a plummet, a ladder going up and a plummet, and a ladder going down. So the first would be more indicative of an age group, and the second one would be what you would get if you divided incorrectly. You wouldn't see the natural trend of, I don't know what this would be, maybe how much food they eat. Hopefully not, because I'm in 50, so I'm right in the middle there, which means I eat a ton of food compared to everybody else. But it's some kind of demographic. Maybe it's mental, maybe it's knowledge, because we hit a certain point and then we start losing, our marbles start leaking out or something. So you start off knowing something, and then as you get older you grow more. But you can see here we lose that. You lose that continuity in the thing if you split the histogram into too many bins or too many buckets. And if you actually plotted this by the individual numbers, it would just be a bunch of dots on the graph and wouldn't mean a whole lot. And we've looked at graphs. There turns out are a ton of useful functions in NumPy. I'm sure there's even new ones that aren't going to be in here. But let's just cover some important ones you really need to know about if you're using the NumPy framework. One of them is line space function. This is generating data. So you have a line space, we have 1, 3, 10, and when we do that, we end up with 10 numbers. So if you count them, there's 10 numbers. They're between 1 and 3, and they're evenly spaced. We get 1, 1.222. But these are all, there's a total of 10 here, and it's right between the 1 and 3 range. That can be, there's a lot of uses for that, but they're probably more obscure than a lot of the other common NumPy arrays set up. Then a real common one is to do summation. So we'll do summation where you do, in this case we create a NumPy array of two different arrays, 1, 2, 3, or 2 different dimensions, 1, 2, 3, 3, 4, 5. And we're going to sum them up under axes 0, which is your columns. And if you remember correctly, columns is the 1 plus 3, 2 plus 4, 3 plus 5, so we have 3 columns. And if we change this, we'll just flip this to 1. We get 2 numbers. So we get 1, 2, 3 all added together, which equals 6, and 3 plus 4 plus 5, which equals 12. We'll set this back to 0. There we go, since we're looking at axis 0. And these probably could have been, some of these could be with our math section. Square root and standard deviation, 2 very important tools we use throughout the machine learning process and data science. And simply we take the NP array, we have again the 1, 2, 3, 4, 5, 6, 3, 4, 5. I don't know why I need to keep recreating it, probably could have just kept it. But we can take the square root of A. So it goes through and it takes the square root of all the different terms in A. And we can also take the standard deviation, how much they deviate in value on there. And there's a rabble function. We can run that. And NP array is x, we're going to do x equals, hey, we changed it from A to x. x equals ravel, and this sets it up as columns. So we have 1, 2, 3, 4, 5. This is all columns on here. Very similar to the flatten function. So they kind of look almost identical, but we also have the option of doing a ravel by column. And then another one is log, so you can do mathematical log on your array. In this case we have 1, 2, 3, and we'll find the log base 10 for each of those 3 numbers. And there's a couple of them. You can't just do any number here after log, but there is also log base 2. Log base 10 is pretty commonly used on here. We'll go and run that. There we go. Before we go, let's have a little fun. Let's do a little practice session here on some more challenging questions, so you start to think how this stuff fits together. Right now we just looked at all the basics and all the basic tools you have. So let's do some NumPy practice examples. And let's start by figuring out how do you plot, say, a sine wave in NumPy. What would that look like? And so in this project we wouldn't have to do this because I've already run these, but we'd want to go ahead and import our NumPy as NP and import our matplot library pyplot as PLT. So we get our tools going here. And then we'll break it into 2 sections because we need our x, y coordinates in here. So first off, let's create our x coordinates. And our x coordinates we're going to set to an A range. And we want this A range, since we're doing sine and cosine, it's going to be between 0 and 0.1. And then we use our NP, and we actually can look up NumPy stores pi. So you have the option of just pulling pi in there directly from NumPy. It has a few other variables that it stores in there that you can pull from there. But we have NumPy pi, and we generate a nice range here. And let's go ahead and run this. And just out of curiosity, let's see what x looks like. I always like to do that. So we have 0.1, 0.2, 0.3, 0.4. So we're going 0 to, in this case, 9.4, 3 times NumPy pi. Remember, pi is like 3 point something, something, something. So that makes sense. It should be about 9. And we're doing intervals of 0.1. So we create a nice range of data. And then we need to create our y variable. And so y is going to simply equal NP, or NumPy.sine of x. And then once we have our x and y, and if we print, let's go ahead and just print y. See how that, we'll do this. Let's do this so it looks print x, print y. So we basically have 2 arrays of data. So we have like our x-axis and our y-axis going on there. And this is simply a plt.plot because we're going to plot the points, and we'll do x comma y, and then we want to actually see the graph, so we'll do plot.show. And we'll go ahead and run that. And you see we get a nice sine wave. And here's our numbers 0 through 9. And here's our sine value, which oscillates between -1 and 1 like we'd expect it to. Then for the next challenge, let's create a 6x6 2-dimensional array and let 1 and 0 be placed alternatively across the diagonals. Oh, that's a little confusing. So let's think about that. We're going to create a 6x6 2-dimensional, so the shape is 6x6 2-dimensional array, and let 1 and 0 be placed alternatively across the diagonals. Now, if you remember from lesson 1, we can fill a whole NumPy array with zeros or 1s or whatever. So we're going to do NP, create a NumPy zeros, and we're going to do a 6x6, and we'll go ahead and make sure it knows it's an integer, even though it's usually the default. And just real quick, let's take a look and see what that looks like. So if I run this, you can see I get 6x6 grid, so 6x6, 0, 0, 0, 0, 0. Now, if I understand this correctly, when they say 1s and 0 placed alternatively across the diagonals, they want the center diagonal, maybe that's going to stay 0 all the way down, and then the next diagonal will be 1s all the way across diagonally, and then the next one 0s, the next one 1s, and the next one 0s, and so on. Hopefully you can see my mouse lit up there and highlighting it. So let's take a little piece of code here, and we'll do z1 colon colon 2 comma colon colon 2 equals 1. And wow, that's a mouthful right there. So let's go ahead and run this and see what that's doing. And so what we're doing is we're saying, hey, let's look at, in this case, row 1. There's 1. And then we're going to go every other row 2, so we're going to skip a row. So skip here, skip here, skip here. So we're going down this way, and we're going every other row going this way. It's hard to highlight columns. So you can see right here where we're not touching each row. Is like this row right here is not being touched. Okay, so we're going to start with row 1, and then we're going to skip a row and another one, and so we're going every 2 rows, and then in every 2 rows we're looking at every 2, starting with the beginning. That's what this thing blank means. So we're going to start with the beginning, and we're going to look at all of them, but we're going to skip every 2. So starting with row 1, we look at all the rows, but we do it by 2 steps. So we go 1, skip 1, 1, skip 1, 1, skip 1, 1. If you left this out, it'd do every one. This would just be ones. In fact, let's see what this looks like. If I go like this and run it, you can see that I just get ones. So this notation allows us to go down each row, row by row, and we're going to do every other row set up on there. And so if we're going to start with row 1, we also, Control Z, try that. There we go. We'll start with row 0. Again, we're going to go each row, step 2. So we'll start with row 0, and we'll go every other row. And this time we'll start with 1, column 1. And again, we go every other one going down. That's what that step 2 is. That's skipping every other one. We're going to set that equal to 1. So let's see what that looks like. And you can see here we get our answer. We get 0, 1, 0, 0. But it has the 1s going in diagonals on every other diagonal and 0 on every other one. A little bit of a brain teaser, that one, trying to get that one to work out. So you can see how you can arrange your rows, and here's your step and your different axis on there. And then the next one is find the total number and locations of missing values in the array. The first challenge is to create some missing numbers. So let's create our array Z. We're going to do numpy.random.rand 10, 10. And before we do the second part, let me just take this second part out. And let's just see what that looks like. So let's run that. And there we go. So we have a 10 by 10 random array. It randomly is picking out numbers. And next, we want to go ahead and take our random integer size equals 5. And then we're going to do a random 10 size equals 5. So in the Z, we're going to select a number of random spaces here and set them equal to null value. And let's go ahead and run that so you can see what that looks like. And if we look at the array, we've created 1, 2, 3, 4. There should be a 5th one in here. My eyes may be failing me. So we've created a series of, because 0 to 5, 0, 1, 2, 3, 4. So we got 5, there are different null values on here. And this is kind of a neat notation to notice that we can generate random integers, size equals 5. So this generates 5 by 5 miniature grid inside of this to tell it where to put the nans at. So that's kind of a cool little thing you can do. And then we want to look up and see how many null values are in there. And this is simply just np is nan of z. Simple. So if it is nan, then we want to sum it up. So we're going to sum up all of the different null values on there. Now let's do one more feature in here, which is really cool. Let's go ahead and print the indexes. So np argware np is nan of z. So we're going to create our own another np array. And let's run this, and we'll see here that it comes up with the 4 indexes. So we did count 4 of them up there. It tells you where they are, 1, 9, 2, 0, 4, 6, 5, 4. And then let's go ahead and run this again. Run, there we go. This time I got 5. That's what we get for random numbers. Another fun one that I always like to do is very similar, because we have np is nan z.sum. So we're summing the number of nans. And we can get the indexes, and you can reshape the indexes. But you can also just do, we'll do an INDS where np is nan of z. And let's just print, let's print that. Print INDS. Let's see what that looks like. And it's very similar to what we have. We have 0, 1, 3, 0, 6, 3, 8, 6, 9, 3. But I've split it into 2 different arrays. So we have our X and our Y kind of coordinates going there. And what I can now do is I can now do Z INDS equals, and at this point You can also, instead of getting the sum, you can get the means or all the numbers and that kind of thing, or the average as it is. So that'd be one thing you could do, and you can pick out the average. That's very common in data science, to get the average and just use that for a value. But we'll go ahead and just set it to 0, and then let's go ahead and print our z and run that. And you can see when we come down here, we have wherever there was a null value, it is now 0. And you can set this to whatever you want. This is another way to replace data or help clean data up, depending on what it is you're doing. So, wow, we covered a lot of stuff. So quick rehash going over everything. We went into there, we looked at array manipulation, changing the shape, how to switch that around. We even had the flatten down there, which remember we have another command lower that's similar. We could change the order by F. Remember, F stands for Fortran, very strange connotation, but there's C and F. C is the standard, and F switches it to a different order. To be honest, I usually have to look it up because I almost never use F, but when you need it, you're like, oh my gosh, what was the other order? Just do a quick Google. So we talked about reshape, making sure that the dimensions are the same. You don't want to have like something that has 12 objects in it and reshape it to 11 and 5 because it doesn't work. It doesn't divide into 12. We can transpose, so we can switch them. So we can go from a 4x3 to a 3x4. Oops, I did that the other way around. 3x4 to 4x3. We covered reshaping the array. We did the roll the axes. You can do some weird things with swapping and rolling axes and transposing the numbers. We dug a little bit into the arithmetic. So we talked about adding, we talked about subtracting, multiplying, dividing. And at this point it's so important we just look up the NumPy mathematics. And you can see here they have just about everything. Your trigonometry, your hyperbolic functions, rounding, sums, products, differences. There are so many, all your different miscellaneous mathematical connotations. So, Google it, go to the main NumPy page and look at the different setups you can do on there. So we covered that, and we did slicing, how to break it apart. We did iterating over the array. We covered joining arrays and how to concatenate. Remember, concatenate just means add on to it. So in this case, how are you adding B onto A is how you'd read that. From Linux, you should catch the concatenate because that's used regularly there. Splitting the array, we talked about how to split the array in different ways. So you can split it in array of arrays, all kinds of different ways to split the array up. How to resize it. And remember, resize does not have to have the same shape, but if you resize it, it will take the data and begin at the beginning and add new rows on if the size is bigger. If it's smaller, it truncates it. It just cuts the end off. We looked at how to do a histogram and how to plot that. We mentioned buckets or bins, as they call them in PyPlot. And then we covered a lot of other useful functions in NumPy. We talked about the line space setup for doing numbers in a series. How to sum the axes up. Again, that's part of the mathematical formulas there that we looked at. There's a sum, there's also means and median. All of those you can compute in NumPy. And you can also do the square root and standard deviation. The ravel function, very similar to the flatten. To be honest, I almost always just use the flatten, but the ravel has its own kind of functionality that it does. And then we went into some NumPy practice examples. We challenged you to create a sine wave in NumPy and how to do that. We're kind of looking for that A range. Remember how we do the A range, and you can have your beginning value, your end value, which they did as 3 times pi, NumPy pi, and we're going to do intervals of 0.1, and then y just equals the NumPy sine of x. There's our math from the math page we were just looking at. Remember that? It's right at the top. And finally we went down here. We had this kind of a little brain teaser, how to do diagonal zeros and ones, playing with the different connotations of the NumPy array. And then we did a random size, and we played a little bit with with the null values, playing with null values. If you're doing any data science, null values are like a headache. What do you do with them? Big sets of data, you get rid of them. Small sets of data, you have to factor something in there, like figure out the average or the median there, and then replace it with that. Pandas really is a core Python module you need for doing data science and data processing. There's so many other modules that come off of it. There actually sits kind of on NumPy, so if you've already had our NumPy array, hopefully you've already gone through the NumPy tutorial 1 and 2. So today we're going to cover what is Pandas. We'll discuss series. We'll discuss basic operations on series. And then we'll get into a data frame itself, basic operations on the data frame, file-related operations on a data frame, visualization, and then some practice examples. Roll up our sleeves and get some coding underneath there. And let's start with just some real general, what is Pandas? Pandas is a tool for data processing which helps in data analysis. It provides functions and methods to efficiently manipulate large data sets. Now, this is a step down from, say, using Spark or Hadoop in big data. So we're not talking about big data here, but we are talking about Pandas, and there is some connections. There's like an interface going on with that, so there is availability, but you really should know your Pandas, because if you're working in big data, you'll know there's data frames. Well, Pandas is a data frame primarily. It has a couple different pieces we'll look at here. And if you've never worked with data frames before, a data frame is basically like an Excel spreadsheet. You have rows and columns. You can access your data either by the row or the column, and you have an index and that kind of setup. And we'll dig more into that as we get deeper into Pandas. But think of it as like a giant Excel spreadsheet that's optimized to run on larger data on your computer. And then I said it that it's a data frame. So the data structures in Pandas are series, one-dimensional arrays, and then we have data frame, two-dimensional array. And it really centers around the data frame. The series just happens to be part of that data frame. And here's a closer look at a Pandas series. Series is a one-dimensional array with labels. It can contain any data type, including integers, strings, floats, Python objects, and more. So it's very diverse. If you remember from NumPy we studied, they had to be all uniform. Not in Pandas. In Pandas we can do a lot more. And Pandas actually kind of sits on NumPy, so you really need to know both of those if you haven't done the NumPy tutorials. And you can see here we have our index 1, 2, 3, 4, 5, and then our data A, B, C, D, and E. Very straightforward. It's just two columns, and we have a nice index label and a column label for the data. And then a data frame is a two-dimensional data structure with labels. We can use labels to locate data. And you can see here we had, if we go back one, we had our index 1, 2, 3, 4, 5. So in each one of these series, they would share the same index over there, the row index. So you have your row index df.index, and then you have a column index df.columns. And this should look, like I said, this would be really familiar if you've done any work with spreadsheets, Excel. So it kind of resembles that. This does make it a lot easier to manipulate data and add columns, delete columns, move them around. Same thing with the rows, so you have a lot of control over all of this. Now, we're of course going to do this in our Jupyter Notebook. You can use any of your Python editors, but I highly suggest if you haven't installed Jupyter and haven't worked with it, it is probably one of the best ways for easily displaying a project you're working on. I skip between a lot of different user interfaces or IDEs for editing my Python, and it's just simply jupyter.org, jupyter.org. And then I always let mine sit on Anaconda, anaconda.com. And just real quick, we'll open that up for you. Oops, offline mode. Don't show me that again. But you can see here that I have different tools that I can actually install in my Anaconda, including the Jupyter Notebook, which comes by default. And then I have access to the environments. And again, that's anaconda.com, named after the very large, one of the world's largest snakes, and then Jupyter Notebook. In this case, jupyter.org. And when we're in I'm going to go in here to our Jupyter Notebook, and we're going to go ahead and just do new and a Python 3. And this will open up a Python 3 untitled folder. So diving right in, let's go ahead and give this a title, Pandas Tutorial. And we'll go up to cell, and we'll change the cell type to Markdown so it doesn't execute it as actual code. One of those wonderful tools when you have Jupyter Notebook so you can do demos with this. And let's go ahead and import Pandas, and usually people just call it PD. That has become such a standard in the industry. So we'll go ahead and run that. Now we have our Pandas has been imported into our Jupyter Notebook. And then, we can go ahead and let me do the Control Plus. Since it's Internet Explorer, I can enlarge it very easily so you have a nice pretty view. Whoops, too big. There we go. And whenever you're working with a new module, it's good to check your version of the module. In Pandas, you just use in this case, pd.__version__. That's actually pretty common in most of our Python modules. There's different ways to look up the version, but that's one of the more common ones. And we'll go ahead and run that. We get 0.23.4, and if we go to the Pandas site, we see 0.23.4 is the latest release. And of course, a reminder that if you're going to your environment, you need to install it. So you'll need to do pip install pandas if you're using the pip installer. We'll go and close out of that. And the first thing we want to do is we're going to work with series. A lot of the stuff you do in series you can then do on the whole data set. We need to do what? Create one. We need to manipulate it, take pieces of it, so query it, delete, so you can delete different parts of it. So we want to do all those things with the series. And we'll start with the series, and then almost all the code, in fact all the code does transfer right into the actual data table. So we go from a series of a single list of one column, and then we'll take that and we'll transfer that over to the whole table. And we'll start by creating, let's put a, there we go, creating a series from list. And let's just call this ARR equals, and we'll do 0, 1, 2, 3, 4. If you remember from our last one, we could easily do R equals range of 5, which would be 0 to 4. But we'll do R equals 0 to 4, and we'll call this S1, and we'll go PD, and series is capitalized. This one always throws me, is which letters do you capitalize on these modules? They're getting more and more uniform, but you got to watch that with Python. And we're just going to go ahead and do ARR. So we're just going to take this Python list and we're going to turn it into a series. And then because we're in Jupyter, we don't have to put the print statement. We can just put S1 and it'll print out this series for us. And let's go ahead and run that and take a look. And you'll see we have 2 rows of numbers. So the first one is the index. Now it automatically creates the index starting with 0 unless you tell it to do differently. So we get 0, index row 0 is 0, 1, 1, 2, 2, 3, 3, 4, 4. And because it's a series, it doesn't need a title for the column. There's only one column, so why title it? And this also lets you know that it's a data type of integer 64. So we print this out. This is our series, our basic series we've just created. And let's do a second series, PD, and we'll use the same data list. And let's go ahead and do order. We'll give it an order equals, let's do it this way. Let's go index equals order. And it helps if we actually give it an order. So we'll do order equals, and let's do 1, 2, 3, 4, 5. So instead of starting with 0, we're going to give it an order starting with 1. We're going to run that, and we'll go ahead and print it out down here, S2. And we'll see that we now have an index of 1, 2, 3, 4, 5, and that represents 0, 1, 2, 3, 4 in the series. And we're still data type integer 64. And very common as you're messing with NumPy arrays is we can import our NumPy as NP. Remember that from our NumPy tutorials. We can go ahead and create a NumPy out of random with the random numbers of 5. And let's just see what that n looks like, so we can see what our NumPy looks like. So we have some nice random float values here, 2.33, so on. And this from our last tutorial, the NumPy tutorial 1 and 2. And instead of calling it order, let's call it index. And we're going to set our index equal to A, B, C, D, and E. I want to show you that the index doesn't have to be an integer, so it can be something very different here. And then let's go ahead and create our, we'll just use S2 again. And here's our NP for NumPy, series, capital S, and N is our NP for NumPy. PD for pandas, there we go, switching my anachronisms. So we have pd.series of n, and we want to do our index equals our index we just created. And then let's go ahead and see what that looks like. S2 is to print it, and let's run that. And we can see here we have a nice series going on. A, B, C, D, and E for our indexes. So instead of it being 0, 1, 2, 3, or 4, we can make this index whatever we want. And you can see the numbers here going down that we randomly generated from the NumPy array. So we used NumPy to create our Pandas series right here. And so continuing on with creating our series, this one I use so often, we create a series from a dictionary. So we have our dictionary. In this case, we went ahead and did A of 1, B is 2, C of 3, D 4, E of 5. So each one of those is a key and then a value. And then we're going to use, let's use S3 equals PD for pandas, series, and then we want to go ahead and just do D in here. Print out S3 here, and let's go ahead and run this. And you can see we got A is 1, B is 2, C is 3, D is 4, E is 5. And it's still of integer 64 because the actual data is 1, 2, 3, 4, 5, and it's all integer 64, type 64. And the last thing we want to do in the creating section of our series is to go ahead and modify the index, because we're going to start modifying all this data. So let's start with modifying the index of the series. And if you remember, let's do a print this time, S1. I'll go ahead and run this. And the reason I did print is because it only prints out the last variable. So if I put S1 up here and we're going to do another variable back down lower, it won't print the first one, just the last one. And we're going to go ahead and take S1, the index, and we're just going to set it equal to a new index. And obviously, the number of objects in our index has to equal the number of objects in our data. And then because it's the last variable, we can go ahead and just do an S1. And let's run that, and you can see how we went from 0 to 0, 0, 1, 2, 3, 4 as our index. We've now altered it to A, B, C, D, and E. So this would be much more readable or might be representational of a larger database you're working with. So cool tools. We've covered creating a database based on a basic array, Python array. We've showed you how to reset the index. Then we showed you how to use a NumPy array. So you can put a NumPy array in there. It's all the same, pd.series, a NumPy array, and then we can set the index on there. And the same thing with the dictionary. So it's very versatile how it pulls in data. And you can pull in data from different sources and different setups and create a new series very easily in the pandas. And then we looked on changing your index. So now we have a new index on here. And then we want to go ahead and do some selection. Let's do some basic slicing, most common thing you'll probably do on here. And we'll just do S1. This notation should start to look really familiar. Again, this is going to put an output, so it doesn't change S1. This just selects it. So we might do A equals S1 and then print A. And you'll see that it just looks at the first three, 0, 1, 2. And we can do the same thing by not having the A in there. I'll go ahead and take that out, but it's just a reminder that it's not actually changing S1. It's just viewing S1. So simple slicing on here. And we can likewise do an append. Oops, before we do append, let's just do a quick kind of fun one. We'll do to -1. And you'll see it covers everything but the E. Of course, you can do -2 on this side. So another way to select it is to go how far from the end. And likewise, we can do a 2 here. A CDE to the end. So it starts at the second one. And another way we can do this is we can do a -2 over here. And that looks at just the last 2 in the slice. So you can see how easy it is to slice the data. And of course, there's no reason to do this, but you could select all of them if you wanted to view all of them on there. Oops, 32. There's not 32, so it's just going to show the first 3. There we go. And then we can also append. So I can take and, let's create another series and append one to it. And if you remember, we had S3. There's our S3. And we have our S1. We'll go ahead and do S1. And let's go ahead and do, let's call it S4 equals S1 append S3. So we're just going to combine those two into S4. And if we go ahead and print S4 on here, you'll now see that we have A, B, C, D, E, A, B, C, D, E, 0, 1, 2, 3, 1, 2, 3, 4, 5, because we started the data at 1. So very easy to append one series to the next. And if we're going to append one series to the next, we need to go ahead and drop or delete one. And drop is the key word for that. And let's just do E, or index E. And so if I run this, you'll see that it'll print it out, and A, B, C, D, there's no E. And remember, all these changes, if I type in S4 again, you'll see that S4 still has E in it. So this change does not affect the series unless you tell it to. So I'd have to do like S4 equals S4.drop E. And there's another way to do that, which we'll show you later on. Let me just cut this one out. There we go. All right, so we've covered all kinds of cool tools here. We have appending, we have slicing. We did all the creating stuff earlier. So you can see here on the setup how easy it is to manipulate the series. So next, what we want to get into is we want to get into operations that happen on the series. Let me go ahead and change this cell to Markdown, there we go, and run that. So series operations, what can we do with a series? And let's start by creating a couple arrays. We'll call it array 1, and we'll do 0 through 7, and array 2, 6 through 6, 7, 8, 9, 5. I don't know why we threw the 5 on the end. Let's go ahead and run those so those load up into Jupyter. And we'll do this a little backwards. We're going to do S5 equals a Panda series of array 2. So I'm doing this in reverse. And then when we do S5, you'll see that we have 0 to 4. It automatically assigned the index. 6, 7, 8, 9, 5 for our series. And let's go ahead and do the same, and we'll call this S6, and we'll set this equal to PD series for our first array. And if we do an S6 down here to print it out, we'll see something similar. I got 0 through 6, 0, 1, 2, 3, 4, 5, 7 for the data. So those are two series we just created, series 6, 5, and 6. And one of the first things we can do is we can add one series to the next. So I can do S5.add S6. And let's see what that generates. And just a quick thing, if you've never used pandas, what do you think is going to happen with the fact that this only has 5 different values in it, and this one has 7 values? So let's see what that does. And we end up with 6, 8, 10, 12, 9, and it goes, oh, I can't add this. There's nothing there. So it gives us a null return. Very different than the NumPy that would have given you an error. This instead tells you there's no value here because we couldn't generate one. So we can easily add S5.add S6, and likewise we can do S5.sub for subtract S6, and we'll run that. And on the add, the subtract, and you guessed it, we're going to do multiply and divide next. Again, you can see there's the null values where it can't subtract the two because there's no values there to subtract. We can also do S5 multiply, MUL. They're all 3 letters on these. That's one of the ways to remember how they figured out the code for this. So remember, these are all 3 letters, mul. We'll go ahead and run this, and you can see how they're multiplied together. And then we can also do the S5 div, 3 letters again, S6, and run that. And you'll see here, this goes to infinity because we have 0 in the wrong position. So it actually gives you a whole different answer here. That's important to notice. And then in the null values, because there's no data and it can't actually produce an answer off of missing data. And since we're in data science, let's do S6 median. So let's look up the median data, which is simply median. Sorry for those who are following the 3 letters, because median is not 3 letters. And you can see in S6 is 3.0. And let's do a print here. And we'll do median or average. S6. And let's print max, comma S6. And just like median, there's max value. And if we're going to have a max value, we should also have a minimum value. So let's pop in minimum. We'll go ahead and run this. And you're starting to see something that would be generated like, say, in R, where you're starting to get your different statistics. We have a median value of 3, max value of 7, and a minimum value of 0. And what it does when it hits these null values, if there is null values in there, because we could still do that, we could actually, you know what, let's go up here and do, let's pick this one where we multiplied. Let's go S7 equals, I'll go ahead and print the S7 just so I keep it nice and uniform, so I still have my S7 down there and run it. And then I want to take the S7, because S7 now has null values and an infinity value, and let's see what happens. This is going to be interesting because I want to see what it does with infinity. And we end up with a median of 6, maximum of 27, and minimum of 0, which is correct. It drops those values. So when it gets to there and it doesn't know what to do with them, it just drops those values and then it computes it on the remaining data on there. So that's important to know when you're making these computations, you're looking at min and max and median, you're not going to know that there's null values unless you double check your data for the null values. That's a very important thing to note on there. So just a real quick review on there. We've created our PD series, and we've gone ahead and done addition, subtraction, multiplication, division. All of those are 3 letters, so sub, min, div, add. And then we looked at median, maximum, and minimum. So we're going to go ahead and jump into the next big topic, which is to create a data frame. So now we're going to go from series, and we're going to create a number of series and bundle them together to make a data frame. There we go, cell type, markdown. And we go ahead and run that. So we have a nice title on there. It's always good to have a good title. All right, so our first data frame, we'll jump in with some stuff that looks a little complicated, but we'll break it down. First, I'm going to create some dates. And you know what? Let's just go ahead and do this. I want you to see what that looks like, what I'm creating here. I've created a series of dates, PD date range, and we're going to use these for the index. Okay, so when you look at this, you'll see that it's just, basically it comes out kind of like a basic Python list or a NumPy array, however you want to look at it, with our different dates going down. And we've generated 6 of them. And it's going to have whatever time it is right now on the thing for the date for the time. That's that time stamp right there. And then you'll see we have 11/19, 2008, 11/20, 11/19, and looking into the future there. So that's all this is generating a series of dates that we're going to use as our index. And this is a pandas command, so we have a date range, which is nice. That's one of the tools hidden in there in the pandas that you can use. And next we're going to use NumPy to go ahead and generate some random numbers. In this case we'll do the np.random.random in 6,4. You can look at this as rows and columns as we move it into the pandas. And of course you could reshape this if you had those backwards on your data. But we want the 6 to match the rows, and we have 6 periods, so our indexes should match along with the rows on there. And then, you know, before we do the next one, let's go ahead and just print out our NumPy array so you can see what that looks like. Here we have it, 1, 2, 3, 4 by 1, 2, 3, 4, 5, 6. 4 by 6. So it's a nice little setup on there. And since working with data frames can be very visual, let's give our columns, we have 4 columns, and we're going to give them names, A, B, C, and D. So now we have columns on there also. And then let's put this all together in a data frame, and we can actually, you know what, let's do this. Since I did it with everything else, let's go ahead and do columns. And you can see there's our columns on there. And we'll go ahead and do df1 equals pandas dot data frame. And note that the D and the F are capitalized. Series, it was just the S, and I always highlight this because you don't know how many times these things get retyped when you forget what's capitalized on there. It's a minor thing. You'll pick it up right away if you do a lot of it. And the first thing we want to do is we want to go ahead and take our NumPy array, because that's what we're going to create our data frame off of, is the NumPy array. And then we want our index equal to our dates. So there's our index in there. And then we also have columns equals columns. And then finally, let's see what that looks like. Now remember, we had all that different data that just looks like a jumble of data. We have our column names and everything else. Our NumPy array, kind of just a jumble array over there, 4 by 6. You can sort of read it. But look how nice this looks. I mean, this is, you come into a board meeting, you're working with your shareholders. This is pretty readable. This is, you know, this is our date. This is our A, B, C, D, whatever it is. Maybe each one of these dates has your leads, closures, lost leads, total dollar made, you know, whatever it is, if it's in a business. Maybe it's measurements on some scientific equipment, weather searching material, you know, where this is like high of the temperature, low of the day, humidity of the day, whatever it is. So you can see that we can really create a nice clear chart, and it looks just like a spreadsheet. You know, we have our rows, and we have our columns, and we have our data in there. Now this one I use all the time. If we're going to create, we can create it like you saw here with our NumPy array. Very easy to do that and reshape it. You can also create it with a dictionary array. So here we have some data, and let me just go down a notch so you can see all the data on there. We have an animal, in this case cat, cat, snake, dog, dog, cat, snake, cat, dog. We have the age, so we have an array of ages. We have the number of visits and the priority. Was it a high priority? Yes, no. And then we're going to take that, we're going to create some labels. We have A, B, C, D, E, F, G, H, I. And what I want you to notice on this is we have a title, animal, and then we have basically a Python list. And these lists, they don't necessarily have to be equal because we can have non-data, you know, np.nan, NumPy array, null value. But we want to go ahead and create labels that are equal to the number in the list. So A, the first cat, B, the second cat, C, the snake, D, the dog, and so on. So we'll go ahead and create our labels, which we're going to use as an index. And we'll call this df, let's do it this way. We'll call this df2 equals PD for pandas, data frame, and then we have our data, just like we did before, and then we have our index equals labels. And if we're going to go from there, let's go ahead and print it out so we can see what that looks like, df2. So let's go ahead and run that. Again, you have a nice, very clean chart to look at. We've gone from this mess of data here to what looks like a very organized spreadsheet, very visual and easy to read. Animal, age, visits, priority, and then A through J, cats and all your different animals, so on and so on. And then when you do programming, a lot of times it's important to know what the data types are. So we can simply do df2 dtypes. And if we run that, we can see that our animal is an object, because it's just a string, but it comes in as an object. Age is a float 64, integer 64, and then priority again is just an object. And exploring this one's very popular. Let's go df2 head, and if we print that out, the df2 head returns the first 5. And we can change this. You don't have to do 5. You might want to just look at the top 2. Maybe you want to look at, let's see, let's do 6. So maybe we want to look at just the top 6 in the database, in your data frame. And you can actually, this creates another data frame. So I could have a df3 equal to df2, and this now takes the df2 and just the first 6 values. So if we do df3, run, get the same answer. And if we do the head of the data, we can also do the tail. It's the same thing. df_tail, you can look at the last, we'll just do the tail, which by default does 5, the last 5. And of course you can just look at the last 3 of those real quick just to see what's at the end of the data. And this is, the tail, I love doing the tail of 1 because I'll have like the index or something like that, and it will just show me the last, whatever the last entry was. You know, looking at stock values, and I might want to look at just the last 5 days of the stock values. I can do that with the data frame tail. And some other key things to look up are the index. So we can do df2.index. And I want you to notice that this isn't a call function. So if I put the brackets on the end, it'll give me an error because index is not callable. It's just an object in there. So we do df2.index. There's also columns. So we can go ahead and let's print this. Remember, the first one's not going to show unless I print it, and then df2 columns. So now we can see that we have our indexes and we have our columns listed here, df2.columns, animal, age, visits, priority. It tells you what kind of object it is, or what kind of data type it is, and they're both object. And then finally df2.values. And again, there's no brackets on the end of df2.values because this is an actual object, it's not a callable function. So we'll go ahead and run that, and it just displays a nice array. A very easy way to convert this back to a NumPy array, basically. So before I go into the next section, let's just take a quick look at what we covered so far with the data frame. We came up here, we created our data frame. We did it from a NumPy array first, setting the columns and the index. The index setting it up is the same as when we set up the series, so that should look very familiar. So is the whole format, the NumPy array, the index dates, and the columns. And remember, in our NumPy array, we're looking at row, comma, column. So 6 rows, 4 columns is how that reads in the data frame. And we went ahead and also did that from a dictionary. In this case, animal was the column name with all the data underneath that column, and then age with that data, visits that data, priority that data. And then of course we added our labels in there for our index. So there's no difference in there, but it automatically pulled the column names. Important to know when you're dealing with a data frame and importing a data frame this way. And then we did looking up dtype. We looked at head and tail, looking at your data really quick. We also did index and columns and values. And note these don't have the brackets on the end. So the next thing we want to do is go ahead, since we're dealing with data science, is we want to go ahead and describe the data. So we have df2.describe to do that, and we're going to manipulate it in just a minute, but let's just see what this generates. And you can see right here we have age and visits. So looking at our data from up above, let me just go all the way up here. Animal, age, visits, priority. And it does a nice job generating your age versus visits, which has all the data. You have your count, your means, your standard deviation, your minimum value, 25% are in this group, 50%, 75, and your maximum value. So this will look familiar as a data science setup with your describe for a quick look at your data frame data. So let's start manipulating this data frame and moving stuff around, and we'll start with transposing. and it is simply capital T for transpose. And when we run that, it flips the columns and the indexes. So now the indexes are all column names and the columns are all indexes, animal, age, visits, priority. So if we had come in here with our data shaped wrong, up above where we had a 4 by 6, we can quickly just swap it if we had it backwards. Not a big deal. And we can also sort our data, something that you can't do, which is more difficult to do with a lot of other packages. In the data frame, it's really easy to do. Take our data frame df2, and we're going to sort underscore values by equals age. And so when we run this, you'll see the default is ascending. So we have 0.52, 2.53, and everything else is organized. So if you look at your indexes, they've been moved around because each index, it moves the whole row, not just the one piece of data is not being sorted. So a very quick way to sort by age our different data in the data frame. And in addition to sorting it, we can also slice the data frame. So I could do df2, and this should look familiar from earlier. We'll just do 1 to 3. So we're going to pull out, oops, it does help if I use a df instead of just d. And we're going to pull up just between 1 and 3. So we have not 0, which is A, but we have B, which is 2, or B, which is 1, and C, which is 2. So 1, 2, and then it does not include 3, which is the standard in Python. And we can even do something like this. We can combine them, which is always fun, because remember this returns a data frame. So if I take df2 dot sort values, and we'll do by equals age. This is just kind of fun. And then I'm going to slice it. There we go. Double check my typing and run it. And now you should see FA, because FA are now 1 and 2 on there. So you can very quickly create a whole string on here which narrows it, that you can sort it, then slice it, and do all kinds of fun things with your data frame. We'll just go back to the original one. Run. There we go. And if we can slice it by row, we can also query the data frame. So we can do df2. And this is a little different because I'm going to create an array within an array. And in this case, we're going to look at, let's do age, comma, visits. So look at the different format in here. We have 1 to 3. So we've done this by slicing by an integer value. And then on here, I've done df2 age, comma, visits in an array. And when I run this, you can see that we get just these 2 columns on here. We get age and visits. So it's a quick way to select just 2 columns or select number of columns you're working with. And if you saw up there, we did the slicing. Almost identical to slice is iLocation, which uses the integer location 1, 3. There's a push in Pandas to move to this particular setup instead of doing just a regular slice. And that's because this can be confusing when we slice 1 to 3 and then we select age and visits. So there is a push to go ahead and move to an iLocation, which does the same thing. You can see here BC, it's the same as up above. There's also a copy command, so we can do df3 equals df2 copy. We're just going to create a straight copy of it. And of course, if we do df3, it'll be the same as a df2 on there. So df3 equals df2.copy. And then let's do df3.isNull. So we're looking for null values. And this will return a nice map, and you'll see that everything is false, except when you go up here under the cat or H, they had a null there. And so if we go, they have a couple up here also underneath of, let's see, the dog. Okay, there's a bunch of nulls in here. There's D up here. So let's look at D down here, and you'll see false, true. There it is. There's our null value. So we can create a quick chart of null values. You can use this to do other things. We can leverage that null value to maybe take an average or something and fill those null spaces with data. And we can also modify the location. So here's our df3 location. And notice this is location, not iLocation. iLocation has I for integer. Location uses the, in this case, the variables on the left. And what we can do on here, and we'll go ahead and just set this equal to 1.5, and then let's pick a spot. Let's go back up here where we had, let's do F age, let's see, what was I looking at? Oh, here we go. Let's do F and age. And up here, F is set to age of 2.0. And we find out that that's incorrect data, so we go ahead and switch to df3. equal, and then we go ahead and print out our df3. And if we go to f and age, it is now 1.5. So we're just changing the value in the df3. And this is changing the actual data frame. Remember, a lot of our stuff we do a slice, and like it returns another data frame. This changes the actual data frame and that value in the data frame. So we've covered location, and iLocation is null. Making a copy, here's our iLocation, which is equivalent of a slice, and also selecting columns. So now we want to just take a little detour here, and let's look at df3 means. And this is kind of nice because you can do this. You can either do this you can select a single column here, by the way. You can just add the column selection right here like we did before. So we could have age, look up the mean, that just creates a series. If I run that, there's our age. But if I take that out, instead of selecting it, we can do the whole setup, and it has age and visits. So why doesn't it have priority or animal? Well, those are not integers, so it's really hard. They're non-numerical values. So what is the average? I guess you could do a histogram, which probably we'll look at that later on. But the only two things we can really look at is age and visits, and we have the average or the mean on the age is 3.375, and the mean on visits is 1.9. And let's do df3 visits. We'll go ahead and still the visits again. And you remember all those different functions we looked at for a series? Well, we can do those here. We can do the sum. So if we run that, we'll see that these sum up to 19. We could also look up minimum. If you remember that from before, the minimum is 1, max. So all that functionality is here. I'll just go back to summing it up and adding it all together. So real quick, we've shown you how to take the series operations and put them into the data frame. And then we can actually, this is an interesting one, we can just do df3 sum, run, and you'll see the different summations on there. It just combines them. I like the way it just combines the strings on there for priority and animal. We've looked at is null. We've also looked at copying, along with the different slices which we talked about earlier. So let's talk about strings. Let's dive into the string setup on there. And let's go ahead and create a string series. String equals PD series. And we just put it right in there. We have A, C, D, A, B, A, C, A. Popped in a null value. Cow and owl. I don't know why they picked cow and owl in the background. Someone must like those animals. And of course we can just do string. If we run that, you'll see, leave the R out, we'll get an error. But if we put it in there, you'll see that we have a simple series. 0A, 1C, 2D. And it automatically indexes it 0 to 8. And then we can go string dot lower. So when we're talking about our data frame, in this case, or our data series string, in this case, we use the string function, str, and we're going to make it lower. And if we go ahead and put the brackets on there, and you'll see that we've gone from capital A, capital C, so on to ABC. And baka, CBA, cow, owl, they were all lowercase already. And of course, if you want to go lower, you can also do upper. And we'll go ahead and run that. And you can see we now have ACD, AAA, baka. Everything's capitalized except for the null value, which is still null. Alright, so we looked at a few basic string. You can see that string functions upper and lower. We're going to jump into a very important topic. I'm even going to give it its own header on here because it's such an important topic. What do you do with missing values? Panda has some great tools for that, so we'll dive into those. We'll work with df4, and if you remember the df copy from above, we're just going to make a copy of df3. And let's just take a quick look at the data we're working with. Oops, df3, forgot the 3 on there. There we go. So here we have our cats, snakes, and dogs. Hopefully not all in the same container, because that would be just probably mean to all of them. So we made a copy. We're going to be working with df4. And the reason we made a copy is we want to go ahead and fill the data. And we just simply do fill NA, and then we're going to give it the value we want to put in there. We'll give it the value 4. So I can run in here, and you'll see now that df4 now has where the NA was, it's filled with the value of 4. Same thing down here. A lot of times we'll compute the mean first. So I might do a mean age equals df4, and then we want to go ahead and do age and dot mean, and then I'll do something like this, df4. I only want to select the age, and I want to fill that with the mean age. And I run in there, and you'll see that our df4 age now has the means in there. Just a quick way of showing you how you can combine these. Let me go back to our original one. There we go. And run that. And keeping with good practices, df5 equals df3.copy. And we'll print our df5, which should be the original one. And then on the df5, we can now drop our missing data. I'm going to simply drop NA, and we're going to use how equals any. So I'm going to drop any row that has missing data in it. And you'll see we had D here with missing data and H. And then let's go ahead and see what df5 looks like when we do that. There we go. And there it is. D is gone, and so is H. So we create a new data frame off of this, missing those values. Now, if you have a lot of data, dropping values is a good way to take care of it because you don't miss some data. If you have not a whole lot of data, you're working with like the IRIS data set or something like that, or something small, you want to start trying to find a way to fill that data in so you don't lose your computational power of the data you got. So just a quick look at processing null values or missing values. You can fill them, usually with the means. Some people use medium or the mode. There's different ways you can fill it. One way is means. And we can also just drop those rows. Those are the two main things we do with missing data. Here we go. We're going to cover next. I so love data frames for this. File operations. It saved me so much time because they have so many different tools for bringing data in and saving data. So when we're looking at the data frame file operations, it's really streamlined. I don't know how many times I'll go on to different data downloads and they'll have Panda download standard on there just because it's so widely used. So let's start with the most common file is a CSV. So we have df3 to CSV or animal. And let me just show you the folders going into. Right now I have some untitled and a few things in here, but nothing labeled animal. So we go ahead and run this, and this has now saved the animal to my hard drive. And you can now see the animal folder up here, and if I, let's do edit with a notepad. Oh, let's open it up with just a regular notepad. There we go. Or WordPad. If I open that up, you can see it's comma separated. Our titles, they don't have an index on the categories on the top. And the index, comma, and then all the different data is separated by commas. Standard CSV file on there. And if we're going to send it to CSV, and notice the format is .to_CSV. And it's just the name of the file we're sending it to. You can also put the complete path. By default, it's going to go whatever the active directory this program's running on. That's why those other folders are in there. So we have our df3 to CSV, and then if we're going to put it in there, we want to also get it back out. And we'll call this one df_animal equals pd read_CSV. I always have to remember it's to_CSV and read_CSV. I always want to do like a capital in there and not the underscore. We're going in here again, it's the active directory. So if I now do print out my df animal, and let's just do the head. We only want to look at the first 3 lines. So if I go ahead and run this, we'll see the first 3 lines, and they should match up here what we saved to our CSV. So very easy to save and import from our CSV files on here. And it turns out df3 also has a to Excel. They actually have a lot of different formats, but old school Excel was real popular for so long, still is. We can go ahead and save it as animal.xlsx. We're going to call the sheet named sheet1, and then I can also do df, we'll call it animal2, and this one's going to come from, and the same format on here. There we go. So we still have our animal xlsx, the sheet1, that's where it's coming from. Index columns equals none. So we're going to suppress the indexing on the columns. NA values, and it'll just assign it's 0 on up on your indexes. So if it says index columns equals none, that's what it does. And then we've added null values because there's null values in here, and we want to just make sure that they're marked as NA. And we'll go ahead and just print out the animal2. There we go. And let's run that. Let's make this. No, let's just do the whole thing. So we'll go ahead and run that. And it probably doesn't help that I completely forgot the read. So animal2 equals pd.read Excel. There we go, Excel. So now we go ahead and run it. And what we expect is happening here. We have the same data frame on here. And if I flick back to my folder, you can now see that we have the animal. One of these is in Excel and one of these is a CSV on here. And so there's our two file types on there. And they have other formats. These are just the two most common ones used, and I don't know how many times I've had stuff from Excel I need to pull out. If you've ever played with Excel, it's a nightmare in the back end because of the way they do the indexing. So this just makes it quick and easy to pull in an Excel spreadsheet. So we looked at two different ways to bring data in and save it to files. We've looked at all kinds of different ways of manipulating our data set and slicing it and creating it for our data frame. Let's get in there for your visualization. Always the big thing at the end, because one, it lets you check to see what you did, make sure it looks right. And then also, if you're going to show somebody else, it makes it very clear what's going on if they see something visual. So this is where a really important part of data science is. So let's go ahead and bring in our tools. We're going to do import NumPy as NP. We want to make sure we have our ampersand matplot library in line. This just lets Jupyter know that we're going to print it on this page. If you're using a different IDE, you don't really necessarily need that, but this does help it displays correctly in Jupyter Notebook. And if you remember for earlier, we could create a, we're going to call it TS. We're going to create a pandas, which are cute, cuddly creatures, versus a pandem, short for pandemonium? No. So we have TS equals PD series, and we're just going to create a random setup of 50. We'll do an index. We'll set it equal to the pandas date range today. Periods equals 50, so the 50 should match. And I want you to notice something here. I did not import the matplot library. Why? Because it's already in there. Pandas already has its built-in connection and interface with matplot library, so you don't have to import it. And we'll go ahead and do TS equals TS dot cumulative sum. We're going to do the cumulative sum. So a little reformatting there, and we'll go ahead and plot it. And let's take a look at what that looks like. So we have a nice graph here. We have the dates on the bottom. We've set this up so we have a nice range between, in this case, -4 to, looks like about 2 maybe, or 1, -4 and 1. So what we've done here, we plotted a basic series, just a single row of data, and we've set indexes on there. But we can also do the whole data frame on there, and let's see what that looks like. So first, let's go ahead and create the data frame. We have here random numbers, so we're going to do 50 by 4. And then we'll go ahead and create columns A, B, X, and Y, just because we can. Index is a ts.index on there, so we're going to use the same index as before, just to keep it nice and uniform. We've already generated the dates to go with it. And then we can do, just like we did with the series, we can also do with the data frame, df equals df cumulative sum. So we're going to sum the whole data frame. And then we'll do simply df plot. And let's push that in, and let's go ahead and run this. And look how easy and quick that was to generate a nice graph with all the different data on there. So we have our shared index, we have the shared columns, and then we have the different data from each one that we can easily look at and compare. So very quick way of displaying data. You can imagine if you were working in, I think I mentioned stock earlier because I've been doing some analysis of stock lately. So you'd have your date down here, and then you would have stock A, stock B, stock XY, whatever it is. And you can put them all on one chart and see how what they look like next to each other. And this isn't too far off from what some of those graphs look like, and this is just randomly generated. So stock has a lot of randomness in it, which is one of the reasons I actually play with it for doing some of my models on, for testing them out. Now, there are a lot of features in Pandas. So we're going to show you one more thing on here. There's some of the things, like I didn't go too deep. We looked at the top two for importing data from a CSV and from an Excel spreadsheet. Showed you how to quickly plot the data. There's more settings in there you can do. We're going to do one more thing down here, and this is kind of a fun one. Change this to a markdown and run that. So how would you remove repeated data using Pandas? And this is where you have a data set that comes in, and maybe it's feeding from one location, and instead of noting that it's repeated the date, like, let's go back to stocks. That's a good visual. We have the stocks from the 23rd. And it adds another row, and it's the same row. It's importing the 23rd again and again. So now you have that data repeated 3 times, and you need to go back and figure out how to get rid of it. How do you track that down? So let's start by creating a quick database, or data frame. Not a database. I keep saying database. It's a data frame. And we'll just make this data frame using our dictionary going in, This data frame only has one data series in it, which is fine. So if we do df to print it out, you'll see A1, 2, 2, 2, 2, 4, 4, 4, 5, 6, 7, and so on. And so how would you remove that? Well, there is a neat feature in data frames called shift, along with another feature that lets us select just certain information. And we'll go with the location function. Put that in brackets. Remember that from above, location. And then in the location, let me just spread this out a little bit so it's real easy to read. In fact, I'm going to go upscale on that since we're doing a little bit more complicated here. What you can see on this, on the location, is I have dfa.shift. So this is going to shift up 1 by default. You can actually change this to 2 or 3. You can even do a -1 and it shifts the other way. But it's going to shift up by 1 by default. And it's going to say if that does not equal df of a, then we want that. And if you look down here, we had 1, 2, 2, 2, 2, 2. When we run this logic on here and we do the shift, it now gets rid of all the duplicates. So we went from 1, 2, 2, 2, 2, 4, 4, 5, whatever it was. Here it is, 1, 2, 2, 2, 4, 4, 4, 5, 5, 5, 6, 6, 6, to 1, 2, 4, 5, 6, 7, 8. And you'll see on the index, it just deletes them out of there so the index stays the same. Obviously, you don't want the dates to change if you're working with an index dated setup. So it just deletes those duplicates out of there. This is just a quick way to introduce you to, 1, the fact that you can add logic gates into here. And 2, the iLocation allows you to use shift. So there's the shift function, and then the iLocation selects that based on true or false. Wow, so we've actually covered a lot today in Pandas. We've really covered into the basics of selecting your different series out of your column, out of your data frame, how to index rows, how to slice, how to plot. Hopefully you'll take this beyond that and start combining these different things, and you can create long strings and really explore your data, generate some nice graphs. If you're in Jupyter Notebook, it's a great demo to show others. And I didn't know this about Jupyter Notebook. You can do this in Jupyter Notebook, and then you can download. And I never really looked too closely at all the downloads. But you can download it as an HTML and post it to your blog. So it's got a neat feature in there. But any of this is really powerful tool. All of this is really powerful tools for doing your data science.
So as you can see, I'm using Jupyter Notebook for the Python. Okay, so here what I will do, I will go to new and the Python 3. Okay, so here first I will rename it to Pandas for data analysis. Okay, then rename it. Okay, so already everyone know Pandas is a Python library that provides extensive means for data analysis, right? Data scientists often work with data sorted in the table formats like .csv, .tsv, or XLX. Okay, so Pandas makes it very convenient to load, process, and analyze such tabular data using SQL-like queries. Okay. So in conjunction with Matplotlib and Seaborn, Pandas provide a wide range of opportunities for the visual analysis. Okay, you can make charts and all, right? So the main data structure in Pandas are implemented with series and data frame classes. So now let me import NumPy first, okay, as np. Then I will write import Pandas as pd. Why I'm writing as np and as pd? Because I don't want to write Pandas and NumPy again and again and again. So I gave the short form, you can say. Okay, so here I will write just pd dot set underscore option display dot precision. Okay, then I will write comma 2. Okay, wait a minute. Okay, fine. So we have imported Pandas and this NumPy library. So now what I will do, I will demonstrate the main method in action by analyzing a data set on the churn rate of telecom operator. I have one data set named telecom churn, okay, operator clients data set. So now let's first import it. Okay, so I will write here df equals to, df means data frame. You can give any name. Okay, df pd As you can see here, PD means pandas. Pandas dot read underscore CSV, then telecom churn dot CSV. So you can find this data set from the description box, okay, in the description box below, right? Then I will write here df dot head. What does this do, df dot head? It will show you, the first 5 lines using the head method of the data set. It will show you first 5 lines of the data set head. And if you will use tail instead of head, you can see the last 5 rows of data set. Okay, if I will write here df dot tail, you can see the last 5 rows of the data set. Fine. Yeah, so on our data set we have state, account length, area code, international plan, voicemail, this. Okay, and the churn rate is false. Fine. So now what I will do, I will recall that each row correspond to one client, an instance, and the columns are the features of the instance. So now let's have a look at the data dimensionally, features, names, and the feature types. Okay, so how many columns and rows we have? Fine. So I will write here print df dot shape. Okay, so now we have 3333 rows and 20 columns in our table, in our data set. Okay, so now let's try printing on the column names using columns. Okay, so for that, what I will do, I will write here print. So these are all the functions used in pandas. Okay, then df dot columns. Okay, so now you can see here we have 20 columns right here, 20 columns. Okay, so here state is one column, account and 3 4, these are the all columns name, these columns name. Fine. So now let's use another function called info, which will give you some, it will give you some general information about the data frame. Okay, so here I will write print df dot info. Okay, so yes, so now you can see class is panda score frame data frame, then this much entries. Okay, 0 to this 3332. Okay, column name and the non-null values, non-null count is 0, and the data types you can see, this is object, this is int64 object, floating type. Okay, so there are 4-5 type of data sets here. Okay, bool is there, float is there, okay, int is there, and the memory usage you can see 498.1 plus KB. Okay, and then bool is 1, float 64 type is 8 columns, then int 64 8 columns, and object is 3, right? So here these bool, int 64, float 64, and object are the data types of features. Already I told you. So we can see that one feature is logical. Okay, that bool one is logical. Where is the bool? Yes, this one. Churn rate is logical. Okay, logical means true false, true false. Okay, and the 3 features are of the object type. You can see this state, these are the object, and the 16 features are numeric. Okay, float is also numeric plus variable, right? So with this same method we can easily see if there are the missing values. So here are none, because each columns contain 3333 observation. See, every column is same, and you can see null count is non-null. Okay, so here you can see we don't need any cleaning and that type of thing. Okay, so we can change the column type with the as type method. There is one more method, so let's apply this method to the churn feature to convert into int64. Got it? So for that, what I will do, I will write df Then I will write churn. Please note that no spelling mistake while writing the column names. Okay, equals to df churn. Okay, C is capital dot as type in 64. Fine. So now we have convert this bool to int 64 now. Okay, so now what I will do, I will use one more method. Okay, let me run it first. Okay, it's no issues. Now what I will do, I will write here df dot describe. Yeah, so now, so the describe method shows basic statistical characteristics of each numeric feature, int 64 and float 64. Okay, count is there for the particular column, the mean, standard deviation, minimum value 25%, 50%, this is the max value. Okay, now you can see the churn 0 and 1 to 1. Okay, so and the number of non-missing values, mean, standard deviation, range, medium, everything is here. Using describe you can just find it. Okay, for every column it will give you. Okay, count, how much count, and mean of this particular account length and the area code, like this. So now, so in order to see the stat of non-numeric feature, so one has to explicitly indicate data types of interest in the include parameter. Okay, I will use the include parameter. So at first I will write df dot describe include equals to object comma bool. Okay, so now you can see the count is 333 and unique values are the 51, and the top is this and the frequency is this. Okay, so I'm here seeing the stat of non-numeric features. Okay, this is like state, international plan, and the voice plan, like this. Fine. So for categorical data like type, object, and the boolean type bool feature, we can use the value counts method. So now let's have a look for that also. So I will write df churn dot value counts. Okay, so this is some data, right? So now what I will do, so there are, okay, fine. So now what I will do here, I will normalize it. Churn dot value counts normalize equals to true. Okay, so we have 2850 users out of 3033 are loyal. Their churn value is 0. Okay, and to calculate fractions pass normalize is equals to true, I have did that to the value count function. Okay, so here you can see 0 and the 1 value counts, right? So now let's go for the sorting data. So what is sorting? So a data frame can be sorted by the values of one of the variables like columns. So for example, we can sort this table by total day charges using ascending or in descending, right? So now I will do here df. Okay, first I will let me write here sorting. Okay, df dot sort values by equals to total day charge ascending equals to false dot head. Dot head means I want to see the top 5 rows. Okay. So now what I did, total day charge. Okay, total day charge. I have sorted in this. Ascending equals to false means I have sorted into the descending order. Okay. And the top 5 rows are this. Okay, 59 is the maximum, 59.64. Fine. So now, like, we can also sort by multiple tables, so in one go. Okay, so let me do it. Df dot sort, same thing I have to write, values by equals to churn. Okay, let me write this. Yeah, churn, comma, then again total day charge, comma, ascending equals to true, comma, false. Then I want to see, okay, let me write the same dot head. Okay, first I will show you this 11111. Okay, then let me change it. See, it's sorted now. Fine. So these are the top 5 as per these two columns, churn and the total data charge column. Okay, so now we will perform some indexing and retrieving data. So a data frame can be indexed in a few different ways. Like, to get a single column, you can use data frame name. Okay, and so now let's use this to answer a question about the column alone. So let's take one question, like, what is the proportion of churned users in our data frame? Okay, proportion. Okay, df dot, we will do simply, we have to find the mean. I will write churn dot mean. That's it. Okay, so 14.5% is actually a quite bad for a company, such as a churn rate can make the company go bankrupt, right? So Boolean indexing with one column is also very convenient. So the syntax is, I will write here df, then again df churn equals to 1, then dot mean. Okay, so here what I am finding is what are the average values of numerical features for churn user. Okay, see, account length just ignore this warning. Okay, so account length is 102.66, area code is this, right? So now what I will do, I will find one more thing. So like, we will find how much time, like in average, do churn users spend on the phone during daytime. Okay, df then churn equals to 1, then total day in minutes. We have this column, right? I hope so. We have this column, total day minutes. Okay, fine. Yeah, dot mean. Okay, so how much time an average churn user spend on the phone during daytime is 206. Okay, almost 207. Okay, so now let's take one more question, like, what is the maximum length of international calls among loyal users? Okay, loyal user means where churn is 0. like who do not have the international plan. So here for that I will write df and df churn equals to 0. Here I will write and df, okay, I will, okay, international plan equals to no, because there is, see, you can see the international plan, no, yes, no, yes, no. Okay, no, then total international minutes. Okay, this, okay, for the confirmation let me copy it and paste. Okay, no issues. Dot maximum value. Yeah, so 18.9. Okay, so 18.9 is the maximum length of international calls among loyal user, whereas churn is 0 who do not have the international plan. Okay, so indexing, data frame can be indexed by column name, I told you already, or the row name, or by the serial number, you can say, of a row. So there is one method LOC. Okay, method is used for the indexing by name, while iloc is another method for indexing by the number. Okay, first I will show you df dot, here I will write indexing, df dot loc comma state, then area code. Okay, so in this first case, we can say I gave the values of the rows with the index from 0 to 5, like inclusive, and the column labeled from the state to area code inclusive. Okay, so this is how you can perform indexing, okay, using by name. Okay, if you want indexing by the numbers, you have to use iloc instead of this loc. Iloc means location. Okay, don't get confused. 5 comma 0 to 3. Okay, see, you got the same almost, right? Yeah, this is 0 to 5, okay, and this is 0 to 3. 0 to 5 means 1 2 3 4 5, and 0 to 3 1 2 3. Fine. Yeah, so what if we need the first or the last line of the data frame? So we can also do that. So here simply you have to write simple thing, df -1. Okay, that's it. See, this is the last line, -1, last line. Fine. So if you want to, apply something to all the columns, so there is one more function which is apply. So how to do is df dot apply np dot max. Okay, right, it gave me all the maximum values of the particular table, sorry, particular column, not table. Okay, so this is how you can do this. So this apply method can also be used to apply a function to each row, I already told you. So to do this, you have to just specify the axis or the lambda function are the very convenient in such scenarios. Like for example, let me give you one example, df, then df state, let's use the state. Okay, then dot apply lambda state and state 0 equals to w, which is starting from w. Okay, then dot, I need only 5 rows, dot it. Okay, so the state is starting from w, here it is. Okay, top 5, right? So yes, so there is one more function, map method, which is used to replace the values in a column by passing a dictionary or the form, right? So map function d equals to no okay, it is false, then yes is true, right? Then df international plan equals to df international plan dot map d. Okay, df dot head. Fine. Okay, there is some international plan. Okay, p is small, that is why I was saying please write it carefully. Yeah, okay, so this is the map function. Okay, so wherever there is no or yes, okay, so I have mapped it to the true false, right? Okay, see here you can see international plan, yes no yes no yes no. I have marked yes to false, and okay, why different? Because the series is different. Okay, here I have performed different thing, the numbers, just check the number. Okay, 0 1 2 3 4, right? df dot head, let me write this. So now let's compare. Okay, why it's coming? Because I have already performed that thing. So we'll go to here, see no 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 yes yes. Now you can see here false 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 true true. So for no I gave false, and for the true, for the yes I gave true. Fine, this is the mapping. This is how you can do the mapping. Okay, so now let's do df equals to, same thing can be done using replace as well. There is one more function. Okay, let me give you the name, stack replace. Dot replace, then voicemail plan, oh sorry my bad, plan d. Okay, fine. Now yes, then df dot. Okay, so what I took, voicemail plan, right? Same, see, true true false false, because here if you will see I have write d equals to this. Again you have to write no to false and yes to true. Same I used here, d, no need to write again and again. Fine. So now let's see how to do grouping. Okay, so first the group by method divides the grouping columns by their values. Okay, first let me write this grouping. Okay, so here I will write columns to show. equals to total day minutes, right, comma total if minutes, comma total night minutes. Okay, then df dot group by, then here I will write churn, then here I will write columns to show dot describe, percentile. Fine, where is it's empty? Fine. Okay, there is error. df dot group by churn by can different describe got an unexpected keyword argument percentile. Okay. Fine. It will be percentiles. Yeah. So this is how you can do the group by with a churn. Okay. So what I did, so let me explain the steps. So first, the group by method divides the grouping columns by their value. Okay. Then they become a new index in the resulting data frame. Then column of interest are selected, column to show, this column to show. Okay, so if column to show is not included, all the non-group by classes will be included. Finally, one or several functions are applied to obtain the groups for selected columns. So here what I did, we group the data according to their values of the churn variable and displays that of 3 columns in each group, right? These 3 columns in each group. Same. Count means standard deviation minimum 50% max. Count means this. Okay. So this is how you can do grouping. Fine. So if you want to summarize the table, okay, suppose we want to see how observation in our sample are distributed in the context or 2 variables, churn and international plan. So to do so, we can build the contingency tables using the cross tab method. I will show you. Okay. So here I will write summary table. pd dot cross tab. Then I will write here data frame df churn comma df international plan. Okay. So this is the true false. The summary. Okay, we have this much true, false, 0 from the international plan, and the 41 are this much. Okay, for one, there are 346 and 137 true, right? So this is how you can perform the summary table, right? You can do for the more also. So now let's create the pivot table. Okay, so let's make the tables. Stack pivot tables. Okay, pivot tables. Fine. So I will add df dot pivot table okay, then I will write here, sorry, yes, so here I will write total day calls, comma, I will take 3 column total if calls, comma, then total night calls, comma, then area code. Okay, comma, then aggregate function equals to mean. Okay, I'm using mean. Fine. So this is pivot, you got the area code and the mean of particular this thing. Right. So data frame transformation. So let me explain you first this pivot table. Okay, before moving forward. So so now we can see the most of the users are loyal and do not additional services. Okay, international plan or the voicemail. So this will resemble pivot table to those familiar with Excel and non, of course. Okay, so here the values are the list of variables to calculate stat for, and the index. Okay, a list of variables to group data by. Okay, area code. Okay, and the aggregate function is what stat we need to calculate for the groups. Like we can use sum, mean, minimum, maximum. Okay, something else. Okay, so here I have used the mean. Right. So now let's predict the telecom churn. Okay, so now let's see how the churn rate is related to the international plan feature. So we will do this using cross tab contingency already saw, and also through visual analysis with Seaborn. I've already told you with Matplotlib and the Seaborn, it pandas is crazy. Okay, so here I will write predicting telecom churn. Okay, so here I will write pd dot cross tab df churn. Okay, C is capital, churn, comma, df international plan, comma, margin equals to true. Okay, sorry, my bad, it's margins. Yeah, okay, we got the pivot table here using cost tab. So I will import here, import matplotlib for the charts. Matplotlib dot pyplot as plt. Then I will import Seaborn. Just remember to install all these libraries. Okay, you can use pip install Seaborn and pip install numpy, pip install pandas before using it. Seaborn as SNS. Then for the graphic retina I will use config inline backend dot figure format equals to retina. Okay, then here I will write SNS dot count plot where x equals to x-axis I'm giving. Okay, international plan, comma, let's set the hue equals to churn, then comma data will be df. Okay, see, we have the counting of using international plan and the hue is churn. Okay, 0 and 1. Fine. So we can see that the international plan, the churn rate is much higher, which is an interesting observation. Perhaps the large and the poorly controlled expenses with international calls are very conflict. Okay, so now let's take a look to another important feature, which is customer service call. Let's also use to to make the summary table first. So for that I will do here pd dot cross tab df churn comma df customer service calls comma margins equals to true. Okay, yes. So again, I have made the summary table for the customer service calls. So now what I will create SNS dot count plot x equals to customer service calls where hue is churn, then data equals to df churn. Yes. Okay, so this is how you can create the charts using pandas and the Seaborn. Fine. So therefore predicting that the customer is not loyal, churn equals to 1 in the case of when the number of calls to the service center is greater than 3 and the international plan is added. Okay, so this is how you can do data analysis using pandas. Okay, web scraping is a powerful technique that allows you to automatically extract data from website, turning the vast amount of information available online into something you can easily analyze and use. Whether you are gathering data for research, building a data set for machine learning project, or just curious about how websites work behind the scenes, web scraping is an essential skill to have in your toolkit. On the other hand, Python is one of the most popular programming languages for web scraping, thanks to its simplicity and the wealth of libraries available. In this video, we will explore how to use Python to scrape data from websites, and we will dive into practical examples using Python libraries like request and Beautiful Soup to fetch and parse web content. But it's not just about the code. Web scraping comes with its own set of challenges and ethical consideration. We will talk about how to scrape responsibly, respecting the rules set by websites, and ensuring that your scraping activity don't negatively impact the sites you are collecting data from. So by the end of this video, you will have a solid understanding of how to start scraping data from the web using Python. Whether you are new to programming or looking to add web scraping to your skill set, this video will give you the knowledge and tools you need to get started. So let's jump in and see how Python can help you unlock the full potential of the web.
So here I am using this Google Colab for the web scraping. Okay, you can use your own like Jupyter Notebook, Visual Code Studio, anything. Okay, so here I will write web scraping using Python. Okay, then here first you have to install some libraries like request, and you have to install Beautiful Soup, and you have to install that pandas, because we will create one data frame and we will save it, then we will check our data. Okay, and you can install some basic Python libraries like NumPy and all that. Okay, so here first I will import request. Okay, then I will write from bs4 import Beautiful Soup. Okay, soup. Then I will write import pandas as pl. Fine. Then now what I will do, okay, let's see what is this request and all the thing. So request is an HTTP client library for the Python programming language. So request is one of the most downloaded Python libraries. Okay, it's like more like over 2000, not exactly 2000, sorry, 200 or 300 million monthly download. Okay, so what it does, it maps the HTTP protocol onto Python's object-oriented semantics. And here Beautiful Soup. So Beautiful Soup is a Python package for parsing the HTML and XML documents, including those with malformed markup. It creates a parse tree for documents that can be used to extract data HTML from HTML, which is useful for web scraping. Let me run it. Here, our second step will be define the URL and the headers. Okay, URL and the headers. So URL, okay, from where you want to extract your data. So I will write here Simplilearn, then this. Okay, let's open this PMP certification. Okay, let's cut it. Yeah. So here I will write this. And headers equals to. So these are the headers. Okay. So like in which device or you are working on, which browser you are working on. So these are for the headers. So now what I will do, I will send a GET request to the Simplilearn page, okay, to this URL. For that, right, let me write this, sending GET request. Okay, here write response equals to requests dot get, then URL comma headers equals to headers. Okay, let me run it. Okay, working fine. So now let's check if the request is successful or not. For that, if response dot status code equals to 200, then so equals to beautiful so. Okay, then response dot content comma HTML dot parser. Okay, here, so here I will write codes titles. Why? Because here I'm initializing the list to store our titles or whatever the things are. Okay, basically the data. Okay, why I'm writing course here? Because this is again course page, that's why, nothing else. Okay, here I will give the empty list. So now we will find all course titles based on the actual HTML structure. What is HTML structure? You have to go to the page, right click, then inspect. Okay, according to this HTML structure means what is the class name, what is the this PMP certification is which heading, H1 heading, H2 heading, which heading it is. Okay, so let's see which heading it is. Okay, this PMP certification training H1 heading. Okay, just remember H1 heading. So here I will write for course info dot find for H1. Okay, then title equals to course text dot strip. Okay, then here I will write course titles dot append title. Okay, now what I will do, I will check if any data was extracted before it not. Okay, I will write if course titles. Here I will create a data frame, df equals to pd dot data frame. In this I will write course title. It will be our that column name. So for I will write it course data. Okay. Then course titles. Okay. Then here I will write df dot to CSV. Then just create Simplilearn.csv. Okay, so our data will be saved in this Simplilearn.csv. Okay, CSV. Fine. Here, what I will do, I will write index equals to false. Print data. Print data is saved in CSV. Simplilearn.csv. Fine. So here I will write else print web page. Okay, write field to retrieve the web page. Okay, that's it. Let me run it. Okay, if response or status group, response object has no attribute, status code. Okay. Okay, title. It is text. Some minor spelling mistakes are there. Okay, dear dot field. Sorry, my bad. Again. Okay, sorry. D will be capital, F will be capital. Yeah. So now you can see data is saved in Simplilearn.csv. So what I will do, I will write data equals to, everyone know how to read CSV in Python. Read underscore CSV. What was our file name? Simplilearn.csv. Okay, let me copy paste, run it, and then find data. Okay. PMP certification training data is fetched. Okay, here you can see H1 we gave, and that's why PMP certification training came. Let's take what's in H2. Okay, in H2 there is leading premier PMI partner, something is there. Okay, I will change here H1 to H2, then I will run it. Okay, fine. See, leading premier PMI. Okay, let me make it big. Yeah. So now you can see course data we mentioned. So if you will see, this H1 didn't come. Why? Because we have mentioned H2. That's why. So these all are the H2. Okay. So what is this? I don't know. Okay. This is a time series graph. This is Google Colab thing. Okay, so this is how you can literally retrieve your data from any website. Okay, just remember that some websites don't give you access to their, for their scraping, just like Amazon don't give. So you have to use at that time API, and this is not ethical also to use someone's data. Okay.
So as you can see, I'm using Jupyter Notebook for the Python. Okay, so here what I will do, I will go to new, and this Python 3. Okay, so here first I will rename it to pandas for data analysis. Okay, then rename it. Okay, so already everyone know pandas is a Python library that provides extensive means for data analysis, right? Data scientists often work with data sorted in the table formats like .csv, .tsv, or XLX. Okay, so pandas makes it very convenient to load,
process and analyze such tabular data using SQL-like queries. Okay. So in conjunction with Matplotlib and Seaborn, Pandas provide a wide range of opportunities for the visual analysis. Okay, you can make charts and all. Right. So the main data structure in Pandas are implemented with series and data frame classes. So now let me import NumPy first. Okay, as NP. Then I will write import Pandas as PD. Why I'm writing as NP and as PD? Because I don't want to write Pandas and NumPy again and again and again. So I gave the short form, you can say. Okay. So here I will write just PD dot set underscore option display dot precision. Okay, then I will write comma 2. Okay, where are it? Okay, fine. So we have imported pandas and this NumPy library. So now what I will do, I will demonstrate the main method in action by analyzing a data set on the churn rate of telecom operator. I have one data set named telecom churn, okay, operator clients data set. So now let's first import it. Okay, so I will write here df equals to, df means data frame, you can give any name. Okay, df pd, as you can see here, pd means pandas dot read underscore csv, then telecom churn dot csv. So you can find this data set from the description box. Okay, in the description box below, right? Then I will write here df dot head. What does this do, df dot head? It will show you the first 5 lines using the head method of the data set. It will show you first 5 lines of the data set head. And if you will use tail instead of head, you can see the last 5 rows of data set. Okay, if I will write here df dot tail, you can see the last 5 rows of the data set. Fine. Yeah, so on our data set we have state, account length, area code, international plan, voicemail, this. Okay, and the churn rate is false. Fine. So now what I will do, I will recall that each row correspond to one client and instance, and the columns are the features of the instance. So now let's have a look at the data dimensionally, features, names, and the feature types. Okay, so how many columns and rows we have? Fine. So I will write here print df dot shape. Okay, so now we have 3333 rows and 20 columns in our table, in our data set. Okay, so now let's try printing on the column names using columns. Okay, so for that, what I will do, I will write here print. So these are all the functions used in pandas. Okay, then df dot columns. Okay, so now you can see here we have 20 columns right here, 20 columns. Okay, so here state is one column, account and 3 4, these are the all columns name, these columns name. Fine. So now let's use another function called info, which will give you some, it will give you some general information about the data frame. Okay, so here I will write print df dot info. Okay, so yes, so now you can see class is pandas core frame data frame, then this much entries. Okay, 0 to this 3332. Okay, column name and the non-null values. Non-null count is
Okay, 0, and the data types you can see. This is object, this is int64, 64 object, floating type. Okay, so there are 4-5 type of data sets here. Okay, bool is there, float is there, okay, int is there, and the memory usage you can see 498.1 plus KB. Okay, and then bool is 1, float 64 type is 8 columns, then int 64 8 columns, and object is 3, right? So here these bool, int 64, float 64, and object are the data types of features. Already I told you. So we can see that one feature is logical. Okay, that bool one is logical. Where is bool? Yes, this one. Churn rate is logical. Okay, logical means true, false, true, false. Okay, and the 3 features are of the object type. You can see this state. These are the object, and the 16 features are numeric. Okay, float is also numeric plus variable, right? So with this same method, we can easily see if there are the missing values. So here are, none, because each columns contain 3333 observation. See, every column is same, and you can see null count is non-null. Okay, so here you can see we don't need any cleaning and that type of thing. Okay, so we can change the column type with the as type method. There is one more method. So let's apply this method to the churn feature to convert into int64. Got it? So for that, what I will do, I will write df, then I will write churn. Please note that no spelling mistake while writing the column names. Okay, equals to df churn. Okay, C is capital dot as type int64. Fine. So now we have convert this bool to int64 now. Okay, so now what I will do, I will use one more method. Okay, let me run it first. Okay, it's no issues. Now what I will do, I will write here df dot describe. Yeah, so now, so the describe method shows basic statistical characteristics of each numeric feature, int64 and float64. Okay, count is there for the particular column, the mean, standard deviation, minimum value 25%, 50%, this is the max value. Okay, now you can see the churn 0 and 1 dual. Okay, so, and the number of non-missing values, mean, standard deviation, range, median, everything is here. Using describe you can just find it. Okay, for every column it will give you, okay, count, how much count, and mean of this particular account length and the area code, like this. So now, so in order to see the stat of non-numeric feature, so one has to explicitly indicate data types of interest in the include parameter. Okay, I will use the include parameter. So at first I will write df dot describe include equals to object comma bool. Okay, so now you can see the count is 333 and unique values are the 51, and the top is this and the frequency is this. Okay, so I am here seeing the stat of non-numeric features. Okay, like state, international plan, and the voice plan, like this. Fine. So for categorical data like type, object, and the boolean type bool feature, we can use the value counts method. So now let's have a look for that also. So I will write df churn dot value counts. Okay, so this is some data. right? So now what I will do, so there are, okay, fine. So now what I will do here, I will normalize it. Churn dot value counts normalize equals to true. Okay. So we have 2850 users out of 3033 are loyal. Their churn value is 0. Okay. And to calculate fractions pass normalized is equals to true, I have did that to the value count function. Okay. So here you can see 0 and the 1 value counts. Right. So now let's go for the sorting data. So what is sorting? So a data frame can be sorted by the values of, one of the variables like columns. So for example, we can sort this table by total day charges using ascending or in descending, right? So now I will do here df. Okay, first let me write here sorting. Okay, df dot sort values by equals to total day charge ascending equals to false dot head. Dot head means I want to see the top 5 rows. Okay. So now what I did, total day charge. Okay, total day charge I have sorted in this. Ascending equals to false means I have sorted into the descending order. Okay. And the top 5 rows are this. Okay, 59 is the maximum, 59.64. Fine. So now, like, we can also sort by multiple tables, so in one go. Okay, so let me do it. df dot sort, same thing I have to write, values by equals to churn. Okay, let me write this. Yeah, churn, comma, then again total day charge, comma, ascending equals to true, comma, false. Then I want to see, okay, let me write the same dot at. Okay, first I will show you this 11111. Okay, then let me change it. See, it's sorted now. Fine. So these are the top 5 as per these two columns, churn and the total data charge column. Okay, so now we will perform some indexing and retrieving data. So a data frame can be indexed in a few different ways. Like, to get a single column, you can use data frame name. Okay, and so now let's use this to answer a question about the column alone. So let's take one question, like, what is the proportion of churned users in our data frame? Okay, proportion. Okay, df dot, we will do simply, we have to find the mean. I will write churn dot mean. That's it. Okay, so 14.5% is actually a quite bad for a company, such as a churn rate can make the company go bankrupt, right? So Boolean indexing with one column is also very convenient. So the syntax is, I will write here df, then again df churn equals to 1, then dot mean. Okay, so here what I am finding is what are the average values of numerical features for churn user. Okay, see, account length one, just ignore this warning. Okay, so account length is 102.66, area code is this, right? So now what I will do, I will find one more thing. So like we will find how much time, like in average, do churn users spend on the phone during daytime. Okay, df then churn equals to 1, then total day in minutes. We have this column, right? I hope so. We have this column, total day minutes. Okay, fine. Yeah, dot mean. Okay, so how much time an average churn user spend on the phone during daytime is 206. Okay, almost 207. Okay, so now let's take one more question, like what is the maximum length of international calls among loyal users. Okay, loyal user means where churn is 0, like who do not have the international plan. So here for that I will write df and df churn equals to 0. Here I will write and df, okay, I will, okay, international plan equals to no, because there is, see, you can see the international plan, no, yes, no, yes, no. Okay, no, then total international minutes. Okay, this, okay, for the confirmation let me copy it and paste. Okay, no issues. Dot maximum value. Yeah, so 18.9. Okay, so 18.9 is the maximum length of international calls among loyal user, whereas churn is 0, who do not have the international plan. Okay, so indexing, data frame can be indexed by column name, I told you already, or the row name, or by the serial number, you can say, of a row. So there is one method, LOC. Okay, method is used for the indexing by name, while iloc is another method for indexing by the number. Okay, first I will show you df dot, here I will write indexing, df dot loc comma state, then area code. Okay, so in this first case, we can say I gave the values of the rows with the index from 0 to 5, like inclusive, and the column labeled from the state to area code inclusive. Okay, so this is how you can perform indexing, okay, using by name. Okay, if you want indexing by the numbers, you have to use iloc instead of this loc. Iloc means location. Okay, don't get confused. 5, 0 2, 3. Okay. See, you got the same almost, right? Yeah. This is 0 to 5, okay, and this is 0 to 3. 0 to 5 means 1, 2, 3, 4, 5, and 0 to 3, 1, 2, 3. Fine. Yeah. So what if we need the first or the last line of the data frame? So we can also do that. So here, simply you have to write simple thing. df -1. Okay. That's it. See, this is the last line. -1, last line. Fine. So if you want to, apply something to all the columns, so there is one more function which is apply. So how to do is df dot apply np dot max. Okay, right? It gave me all the maximum values of the particular table. Sorry, particular column, not table. Okay. So this is how you can do this. So this apply method can also be used to apply a function to each row. I already told you. So to do this, you have to just specify the axis or the lambda function are the very convenient in such scenarios. Like for example, let me give you one example. df, then df state. Let's use the state. Okay. Then dot apply lambda state and state 0 equals to w, which is starting from w. Okay, then dot, I need only 5 rows, dot it. Okay, so the state is starting from w, here it is. Okay, top 5, right? So yes, so there is one more function, map method, which is used to replace the values in a column by passing a dictionary or the form, right? So map function d equals to no okay, it is false, then yes is true, right? Then df international plan equals to df international plan dot map d. Okay, df dot head. Fine. Okay, there is some international plan. Okay, p is small, that is why I was saying please write it carefully. Yeah. Okay, so this is the map function. Okay, so wherever there is no or yes, okay, so I have mapped it to the true false, right? Okay, see here you can see international plan, yes no yes no yes no. I have marked yes to false, and okay, why different? Because the series is different. Okay, here I have performed different thing. The numbers, just check the number. Okay, 0 1 2 3 4, right? df dot head. Let me write this. So now let's compare. Okay, why it's coming? Because I have already performed that thing. So we'll go to here, see no 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 yes yes. Now you can see here false 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 true true. So for no I gave false, and for the true, for the yes I gave true. Fine. This is the mapping. This is how you can do the mapping. Okay. So now let's do df equals to, same thing can be done using replace as well. There is one more function. Okay, let me give you the name. Stack replace. Dot replace, then voicemail plan. Oh, sorry, my bad. Plan D. Okay. Fine now. Yes. Then df dot. Okay. So what I took, voicemail plan. Right? Same. See, true, true, false, false. Because here, if you will see, I have write D. D equals to this. Again, you have to write no to false and yes to true. The same I used here, D. No need to write again and again. Fine. So now let's see how to do grouping. Okay. So first, the group by method divides the grouping columns by their values. Okay. First, let me write this grouping. Okay. So here I will write columns to show equals to total day minutes, right, comma, total if minutes, comma, total night minutes. Okay, then df dot group by, then here I will write churn, then here I will write columns to show dot describe, percentile. Fine. Where is it's empty? Fine. Where there is error. df dot group by churn by can different describe got an unexpected keyword argument percentile. Okay. Fine. It will be percentiles. Yeah. So this is how you can do the group by with a churn. Okay. So what I did, so let me explain the steps. So first, the group by method divides the grouping columns by their value. Okay. Then they become a new index in the resulting data frame. Then column of interest are selected, column to show, this column to show. Okay. So if column to show is not included, all the non-group by classes will be included. Finally, one or several functions are applied to obtain the groups per selected column. So here what I did, we group the data according to their values of the churn variable and displays that of 3 columns in each group. Right? These 3 columns in each group. Same. Count means standard deviation minimum 50% max. Count means this. Okay. So this is how you can do grouping. Fine. So if you want to summarize the table, okay, suppose we want to see how observation in our sample are distributed in the context or 2 variable, churn and international band. So to do so, we can build the contingency table using the cross tab method. I will show you. Okay, so here I will write summary table. ed dot cross tab, then I will write here data frame df churn, comma df international plan. Okay, so this is the true false, the summary. Okay, we have this much true false 0 from the international plan, and for the one are this much. Okay, for one there are 346 and 137 true, right? So this is how you can perform the summary table, right? You can do for the more also. So now let's create the pivot table. Okay, so let's make the tables. Stack pivot tables. Okay, pivot tables. Fine. So I will add df dot pivot table. Okay, then I will write here. Sorry. Yes. So here I will write total day calls, comma, I will take 3 column total eve calls, comma, then total night calls, comma, then area code. Okay, comma, then aggregate function equals to mean. Okay, I'm using mean. Fine. So this is pivot, you got the area code and the mean of particular this thing, right? So data frame transformation. So let me explain you first this pivot table, okay, before moving forward. So so now we can see the most of the users are loyal and do not additional services, okay, international plan or the voicemail. So this will resemble pivot table to those familiar with Excel and non, of course. Okay, so here the values are the list of variables to calculate stat for, and the index, okay, a list of variables to group data by, okay, area code. Okay, and the aggregate function is what stat we need to calculate for the groups, like we can use sum, mean, minimum, maximum, okay, something else. Okay, so here I have used the mean, right? So now let's predict the telecom churn. Okay, so now let's see how the churn rate is related to the international plan feature. So we will do this using, cross tab contingency, already saw, and also through visual analysis with Seaborn. I've already told you with Matplotlib and the Seaborn, pandas is crazy. Okay, so here I will write predicting telecom churn. Okay, so here I will write pd dot cross tab df churn, okay, C is capital, churn, comma, df international plan, comma, margin equals to true. Okay, sorry, my bad, it's margins. Yeah, okay, we got the pivot table here using cost tab. So I will import here, import matplotlib for the charts, matplotlib dot pyplot as plt. Then I will import Seaborn. Just remember to install all these libraries. Okay, you can use pip install Seaborn and pip install numpy, pip install pandas before using it. C1 as SNS. Then for the graphic retina, I will use config inline backend dot figure format equals to retina. Okay. Then here I will write SNS dot count plot, where x equals to x-axis I'm giving, okay, international plan, comma, let's set the hue equals to churn, then comma data will be df. Okay, see, we have the counting of using international plan, and the hue is churn, okay, 0 and 1. Fine. So we can see that the international plan, the churn rate is much higher, which is an interesting observation. Perhaps the large and the poorly controlled expenses with international calls are very conflict. Okay, so now let's take a look to another important feature, which is customer service call. Let's also use to to make the summary table first. So for that, I will do here pd dot cross tab df churn comma df customer service calls comma margins equals to true. Okay, yes. So again, I have made the summary table for the customer service calls. So now what I will create SNS dot count plot x equals to customer service calls, where hue is churn, then data equals to df churn. Yes. Okay, so this is how you can create the charts using pandas and the C1. Fine. So therefore, predicting that the customer is not loyal, churn equals to 1 in the case of when the number of calls to the service center is greater than 3 and the international plan is added. Okay, so this is how you can do data analysis using pandas.
Now we enter the module 1. So the module 1 will be about the introduction to SQL and database basics. So what is SQL is our first question, and why is it important? So today, SQL in simple terms, or let's expand as structured query language, is the standard language used to store, manage and retrieve data from relational databases. In very simple terms, SQL acts as a communication layer between humans and databases. Instead of manually browsing data through files or spreadsheets, SQL allows us to ask precise questions to the large data systems and receive accurate answers almost instantly. You can think of SQL as the grammar of data, because just like grammar helps us form meaningful sentences, SQL helps us form meaningful data queries. So through SQL, we instruct databases to perform critical operations such as searching for specific information, updating existing records, inserting new data into the entries, deleting or removing outdated data, and organizing information using tables, views, and schemas. Without SQL, interacting with structured data at a scale would be slow, manual, and completely error-prone sometimes. Now, why is it important? SQL turns raw data storage into an intelligent, queryable system that businesses completely rely on. Now, you might be wondering, why SQL still dominates in 2026 despite hundreds of new technologies and tools and frameworks emerging every single year. So the answer is SQL continues to dominate the data ecosystem in 2026 and in future because this is not by accident. Because SQL solves a fundamental problem: reliable access to structured business data, universal adoption. Every major organization, whether it's Google, Amazon, Meta, banks, hospitals, or e-commerce platforms, they rely on SQL-powered databases at their core. Even modern cloud-native systems ultimately store their most critical data in relational databases using SQL, and they also query that data using SQL. Next is standardized language. SQL allows ANSI standards, which means once you learn SQL, the same knowledge applies to MySQL, PostgreSQL, SQL Server, Oracle, Snowflake, BigQuery, Redshift, and many others. This portability makes SQL a career-safe skill that remains relevant across tools and companies. Next is essential for analytics and AI pipelines. In analytics and AI workflows, SQL is often the very first step. Before any dashboard, machine learning model, or AI system is built, SQL is used to extract clean, structured, and reliable data. In many ways, SQL is the foundation layer for data-driven intelligence. After that, we have high performance with massive data. Modern SQL engines are highly optimized and can process millions or even billions of rows of data in just mere seconds. Features like indexing, query optimization, and parallel execution make SQL extremely efficient for large-scale data operations. Now, the next question is, where do you see SQL in real life? Although users rarely see SQL directly, it silently powers many everyday systems we interact with. Whether you book a flight, withdraw some cash from ATM, place an online order, or check your bank statement, SQL queries are running behind the scenes. SQL also supports food delivery applications, telecom recharge history, hospital records, and customer support systems. Each of these systems rely on fast, accurate retrieval of structured data, which SQL excels at. A useful real-life analogy is to think of SQL as a remote control for business data. Successful learners who master SQL gain the ability to instantly switch to exact channel of information they need, whether it's sales data, customer retention, or customer records or transactional history, without delay or dependency on others. So the next one is types of databases. So we have two types: relational databases or RDBMS and non-relational ones. Let's get started with RDBMS. A relational database stores data in tables made up of rows and columns, similar to Excel spreadsheets, but with far more structure, rules, and reliability. Each table represents a specific entity, and relationships between tables are clearly defined. Relational databases enforce consistency through constraints and relationships, ensuring that data remains accurate and reliable even as systems scale. They follow ACID, or popularly known as asset properties, which guarantee transaction safety, making them ideal for business critical operations. Since relational databases are SQL based, they allow precise querying and strong validation and predictable behavior. Most popular examples include MySQL, PostgreSQL, SQL Server, Oracle, and MariaDB, all of which are widely used in enterprise systems. Now let's discuss the second type, which is non-relational databases, or simply known as NoSQL. Non-relational databases, commonly known as NoSQL databases, store data in formats designed for flexibility, scalability, and speed rather than strict structure. Instead of fixed tables, they often use JSON documents, key value pairs, columns, or graphs. These databases are designed to handle large volumes of semi-structured or unstructured data and are commonly used in microservices, IoT platforms, real-time applications, and distributed systems. Some of the popular examples include MongoDB for document storage, Redis for key value access, Cassandra for column-based storage, and Neo4j for graph-based relationships. NoSQL systems trade strict consistency for flexibility and scalability in many use cases. Now, in the next stage, let's discuss the basic fundamental differences between relational and non-relational database systems. So, relational versus non-relational analytical comparison. Relational databases focus on structured data, predefined schemas, and strong consistency. They are ideal for transactional systems, reporting, and business logic where accuracy is critical. SQL serves as a powerful and standardized query language in this ecosystem. Non-relational databases, on the other hand, prioritize flexibility, horizontal scaling, and high-speed access. They allow schema changes without downtime and are better suited for rapidly evolving data models. A strong analogy is to think of RDBMS as a well-organized library where every book has a catalog number and fixed location. NoSQL is more like a creative studio where items can be placed freely based on immediate needs without any rigid structure. So, what is RDBMS? A relational database management system is specialized software designed to store structured data and manage relationships between different data entities. It acts as an engine that processes SQL commands and ensures data remains consistent and secure. An RDBMS is responsible for enforcing rules, managing user access, and handling backups, recovering from failures, and even ensuring that multiple users can work with the same data simultaneously without any conflicts. In short, the RDBMS is the backbone that makes SQL reliable, scalable, and safe for enterprise use. Tables represent real-world entities such as customers, products, or orders. Each table focuses on a single concept, keeping data organized and easy to manage. Next is columns. Columns define the attributes of an entity such as name, email, or city. Each column has a specific data type and rule set that governs what value it can store. Rows. Rows represent individual records within the table. Each row captures a complete instance of an entity, such as a single customer or transaction. Next is the primary key. Primary key uniquely identifies each row in a table, ensuring no duplicates exist and enabling efficient data retrieval. Foreign keys create relationships between tables by linking related records, helping maintain consistency across the database. Next is indexes. Indexes function like a book index, allowing the database to locate data quickly without scanning every row. Followed by that, we have constraints. Constraints enforce data quality rules such as not null, unique, and check. These rules help preventing invalid data entry entering into the system. Now, the next stage is why RDBMS is the industry standard. RDBMS systems are highly reliable and trusted for business operations that cannot afford data errors. They enforce data integrity, support normalization, and handle complex transaction workflows efficiently. Because of these strengths, companies use RDBMS platforms for mission-critical applications like billing systems, HRMS, ERP solutions, inventory management, and logistic platforms. When accuracy, consistency, and reliability matter, RDBMS remains the preferred choice. Now comes the next stage where we will learn the installation and setting up SQL environment. So now we have come to a stage where we will install MySQL into the system. Now it's really simple. All you need to do is just type down MySQL Workbench on your browser, and then you'll be redirected to this particular page. Use the first link, MySQL Workbench, or you can also go with the download option. And here you have the download now option, right? So you can click on this and your installation file or the setup file will be downloaded for you. And you just have to run that particular file. It's a simple installation procedure. But if you have any queries, don't worry. I'll also drop a link to this particular tutorial on how to install and run MySQL Workbench. For now, we have already installed MySQL. So let me run that. So this is my database, which is SLP database. So you can see on the right hand corner of my screen, we have an option that says the position of all the prompts and all the sections of this particular workbench. So I'll go with the first option where I can see all the databases I have and the tables I have, right? So right now we are in the table that we earlier created for interview questions and answers. So this will be down the line. So let's go to any of the databases. I would like to go with this particular one, sample dataset. So I'll be using the SLP database. So we can test our SQL database in this way. You can start by selecting any of the databases. Don't worry, in the upcoming section or at the upcoming module, I'll explain you how to load the data how to create table, how to insert the values into your table, and all those fundamental things. So first, for the beginning section, to test our SQL installation, we'll do this. So before you get into anything, you just need to select the database where you have the data. So you can do that by simple command which says use the database name. This is the font. So let's say use and database name. And you need to have a semicolon, right? So you can also see why I'm using specific format. I'm using, let me expand my screen. I'm using all caps for the keywords. In SQL, we have keywords and also the user-defined words, right? So the keywords are something which carry a functionality. So here, if you see, we have a select, from, where, not in, right? These are keywords. They have specific functionality. And whatever the things you see in a black color, which have, case sensitivity in lowercase or sentence case, those are the ones which I define. So tomorrow, if my query gets a little more complex, so down the line, we will be learning subqueries and advanced querying functions, where we should be at a stage where we should identify our own code. If you follow or some mixed kind of way to write your queries, then you might fall into a confusion understanding what is what. Is it a keyword, or is it a word that I define, or is it the name of the column, or anything, the name of a table which I define? So to avoid such confusions, we will follow this standard. If ever there is a keyword, just keep it in all caps. And if ever there is a column name or a table name, then you can keep it in mixed case or low case as per your requirements. So product ID, this particular name is a column name, so that I identify it as a column name, I'm using mixed case there. So it has a caps thing, and then the all small letters in that way. So basically, you need to select a database name and explain MySQL workbench that I'm going to dive into this particular database, which is SLP. And you can see I have complete access here. So if I expand this particular section, you can see SQL gave me a green to go, and then I can also check what are the tables present in my database. So for that, you will be using show tables, control enter, and these are the tables which I have: bonus, book collection, book order, clone, consolidated student information, employee details, etc. So now, if I want to understand employee details, what I'll do is copy this row, copy field, and then I'll simply write down a select statement, right? We will also understand what exactly does select from, and every aspect, every syntax of the statements in the upcoming module. But now we are just testing the condition of the installation that we have done. So for that, so I'll be writing down select. So you can see when I type, you can see some auto suggestions, but don't take any auto suggestions. Follow a strict format for yourself. So select star, which means all the columns. So maybe I'll be having 5 columns, 6 columns in this particular data set or data table. When I indicate star, automatically MySQL Workbench will understand that user wants to query or extract all the columns from the table. If I dedicatedly provide, let's try that as well. So from, and remember the field that we copied, just paste it and remove the single quotes. And at the end, yeah, without semicolon, your query will run. But to follow a strict syntax, we need to enter semicolon. Now, let's hit enter to find out the entries in our data set. So we have 5 columns. You can see we have employee ID, employee name, age, department, and salary. So now, let's say I just want the employee name and their department. In that case, what I can do is quickly copy this and paste it somewhere here. And instead of star, I will write the dedicated column name, EMP name, comma. If your intention is to extract specific columns, then you need to specify them and separate them using a comma. Now I want employee name and department, so I'll write EMP name column, comma, separated, both are separated by comma, and department, right? So let me run this and I'll have, okay, there was some error, copy field name, and I'll paste it here. Yeah, I think that was a small spelling mistake, not to worry. Enter. There you go. So we have John Doe and all the other employees, Jane Smith and Michael Johnson, and their specific departments. Now let us understand something a little more detailed. Let's say the user wants to extract specific employees from IT department. How do we do that? We do that by adding a where clause. So these are clauses, don't worry. We're just testing it out. In the upcoming module, we will be going deep diving into each and every part of this. So where our department is IT. So since this is a character data type, it will be inside quotes. So IT semicolon. Remove the semicolon and everything is good to go. Enter. And we will have the details of all the employees who are in IT department. So this is how a basic query on a MySQL Workbench works. Now we have a briefing on the understandability and working functionalities of the MySQL Workbench. Proceeding ahead, we have the choice of SQL engine for learning purposes. So MySQL and PostgreSQL both are excellent choices. MySQL is known for simplicity and ease of use, making it ideal for beginners and web applications. On the other hand, PostgreSQL offers more advanced features and widely used in analytics and data engineering roles. Both databases are open sources, stable and production ready, making them perfect environments for learning SQL fundamentals. Now we have common installation issues and fixes. Beginners often face issues like port conflicts, authentication mismatches, or missing environment values. So these will be the common issues that you might be facing during the installation process. Don't worry, we will be linking the complete installation and setup video in the description box below. You can go through that, and it will have all the mistakes and all the possibilities of creating mistakes and all the permutations and combinations of the problems that you might be facing in real-time installation. It's a completely detailed tutorial, so it might take a lot of time of this particular session. So for that purposes, we have created a dedicated tutorial for installation. So we will be linking that. Now, why these issues come? Because you might be having Jupyter Notebook or any other platform that deals with databases like MySQL as well. So you might have to dedicatedly create a port for their access. So if there is a port conflict or any kind of authentication mismatch, you might face these. So you have that all covered in that session. Understanding these errors early prevents frustration and builds troubleshooting confidence. Addressing problems such as 3306, which is a port number conflict, or PG admin setup, which is for PostgreSQL failures, helps learners become self-sufficient and comfortable with database tools. Now let's go through best practices for beginners. So some of the best practices are: you should learn always to create a dedicated practice database to avoid accidental data loss. Using meaningful table name and column names improve readability and long-term understanding. Backing up data before experiments and maintaining a personal SQL notes file helps reinforce learning and builds good habits from the start. And that brings us to the end of module 1, and next will be the module 2. So now we have entered module number 2. So this module number 2 gives us a brief introduction to the basic commands in SQL. So this is all about how to create a table, how to insert data into a table, and then when you start querying, how do you query, right? For a basic example, you have select. So select in SQL means you're trying to explain the SQL workbench that you want to select something from a table that you just created. So there might be many number of tables. For this sample execution, we're going to create 5 tables, and you must specify which table are you focusing on, right? So for that, you might have to give SQL table name along with the select statement. And then what do you want to select? You want to select a specific column or all the columns available. So there are again specific ways to select the columns again. If you want any particular column from the table, you need to specify the column name. Or if you want to extract all the tables, then you don't have to write all the column names. You just write an asterisk, and then all the values will be extracted for you. And if you want to filter out, let's say there is a condition where you want to filter out all the employee details where department is equals to HR, then you will go ahead with one filter query, which is where, right? That particular where is a clause in SQL. So this can help you understand how simple SQL is. It's just a verbal language. You talk to your database and you'll get the queries. It's as simple as that, right? This is what makes SQL so exciting, so resilient, so reliable, and so relevant to the current IT standards and industry standards wherever data is related to it. So now without further delay, let's start by creating a simple table, right? So now you can see on my screen, we might have to use the database first. I have already created a database on the name interview, and this particular database will be used by us in upcoming modules, maybe 2 or 3 times for interview questions and answers and joins. And for now, we are just working on the basic terms of creating and filtering data and extracting data insights. So I'll be using this particular data set. And if you want to create a new data set, it's really simple. You go to File, and here you create a new model. And then you add the names to your model and all those things. Or you can also go ahead with this particular option. Create a new schema. And then you name your schema as sample SEHEMA test now. And then you can choose a default location and all those default things for yourself, and then apply. And then you create a schema if you want, apply and finish. For now, I don't want to create this one, so I'll just close it. And once you create the schema, everything is straightforward, like we are going ahead with now. So once you create a database, you need to remember the database schema name. So now I've created this particular interview schema. So to begin with adding any of the tables or adding any of the data entries, I need to specify the database I'm using. So you can see on the left hand side, we have a lot of data schemas. We have car dealership, credit card data, interview, sample stop, right? This is the one sample schema test that we recently created, right? You can drop this schema, drop now. So we have removed it. That's the way you delete a schema if you want. Okay, let's take it as a learning step in case if in future if you wanted to delete any schema. So now I want to get the access to interview schema, or the one which I created already. So how do I get access to it? Again, SQL is really simple. You just need to write down use schema name, which is interview. Done. Semicolon. Now SQL understands, yeah, user wants me to use this particular schema on the name interview. So let me expand this so that you can see it better. I hope the code is visible clearer. So now you can select the entire query and use this particular flash logo to execute, or the best way I use is hold Control and press enter. That is the best way, or a shortcut to select the database. Now comes the next step where you want to create a database. So again, let me tell you this. So we have linked this particular code document in the description box below. You can open up the code document and follow along with us so that you have a better learning experience. And I've also saved this particular code documentation on a notepad for quick access. But before going with the quick access, let us manually type the table names and enter the data or the insert commands so that we have a decent understanding. Let's go back. So the first table that we will be creating is departments. Now you can see this particular double code, right? If you have programming background, then you might have something called naming conventions or tagging or quoting, right? It will not be executed in real time, but it will act as a note or a sticky note that you leave on your code so any of your fellow developer understands what's happening here. So I'm using these double hyphens here as a quote so that my fellow developer will understand. That I'm creating a data table which is named as department. So the simple command for this is create. So you want to create something, so you just write create. What do you want to create? I want to create a table, right? So you can see that whenever we write something, we are using, or I'm using, a separate naming convention, right? So here you can see I used uppercase for the keyword use. So anything which is getting highlighted as in a blue color is a keyword. A keyword has a dedicated meaning and it cannot be used for normal purposes. It can be used only for SQL purposes only, to make SQL understand what is your step or what is your intention. So use uppercase for all the keywords and use mixed case or sentence case or lowercase preferably for your names, right? For the table names, for the column names, for the row entries, or anything which is from your end. Basically, anything which you are giving, the users which you are giving to SQL should be in lowercase so that you can differentiate. For now, we are just trying to write 2 or 3 lines of code, 2 or 3 lines of query. That is easily understandable. But in future, you will be writing subqueries, you will be writing joins, and a lot of more complicated queries where at least you'll be writing 10 to 12 lines of code. In that particular scenario, you must be capable to understand which is a keyword and which is a user-defined word or a name or a column name, right? So a metadata basically. So that's the naming convention you should be following. So understand what's the difference between a keyword and what's actually the name that you have given to your column name or a table name, which is basically user-defined. So you can take it in programming terms, which is user-defined, which is internal implicit design, right? Implicit function. So I want to create a table. So write create table. And what's the table name? So my table name is departments. So this is my table name. So what do I have inside my table is my next question. So inside my table, I want to have a couple of columns. Let's say 2 columns, department name and department ID. So for that, I need to write down dpt ID and data type is integer. I want to provide integer data type for it. So basically, before we continue, let me tell you something. So whenever you want to add columns, you need to add column name. Okay, let me comment this. Column name along with its data type. So this is a set. So whenever you try to enter a column name, you should follow this particular approach where SQL understands this is a, it's a combination. It's an entity which is made of 2 things, name of the column and what's its data type, right? So this is the naming convention that you should be following. So I want department ID as the first column and the next column is department name, right? So for this particular department name, I want to go ahead with varchar, and varchar is also another data type. And for that data type, you can allocate number of locations to save that particular department name. So for a basic request, I think I'd like to go with 50 character spaces, and that should be good enough for writing my department names. And then you can close the command and write a semicolon to end the query. So your query will run without a semicolon, but for safer programming practices, consider it as a protocol so that you or any other developer who is reading your commands will understand that it is the position where this particular query ends. So use a semicolon for that. This is pretty good, but remember, we might have to work on joins in the future modules. So joins is nothing different from the VLOOKUPs or the relationships or the data modules that you have seen on Power BI, Excel, etc. Basically, you're combining 2 or 3 different tables together. Let's say you are ordering something from your online websites, and for getting that particular product to your location, you're providing your address, phone number, and all the details, right? So in a similar way, when you want to access data from a different table, you might have to establish a connection between them. So to establish a connection between the 2 tables, you might want something called as a primary key and a foreign key. So primary key and a foreign key act as phone numbers or an address location, or basically something which establishes a relationship between them. So now this particular thing you need to understand. A primary table in one table is the one which connects with the same primary key in another table, but in the other table it is termed as a foreign key. In my table, department ID would be the primary key. It will be unique and it will not be null. And this particular department ID can also be another table. It can also be unique. It can also be not null, and it will not be empty. But in that particular table, it will be termed as foreign key. The same primary key in a different table is termed as foreign key, but the same primary key in the dedicated table is termed as a primary key. So now I want to term my department ID as the primary key in my table. For that, You just need to write one more sentence here, not even a sentence, one more word. You just need to specify primary key, and that's done. So primary key and done. Now what happens is SQL will understand you want to create a table and the table name is departments, and you have one department ID column, two department name column, and the data type for department ID is integer and the data type for department name is varchar, and you have provided 50 spaces or 50 data spaces or addresses for you naming your department name, right? And out of which department ID is the primary key. So these are the details that you have given to your SQL workbench, and you should be ready to create a new table. So now let's head back to the notepad where we had created the code. This is the one. So create table, departments, ID is equals to int primary key, department name is varchar, 50 locations, and semicolon. So only difference is there are some indentations done. So what is an indentation? Just like any other programming, you also provide dedicated spaces, new lines, so that the fellow developer understands where is what. So this is the indentation we have followed here. We are creating a new table, departments, and the first column is department ID. It is an integer data type and it's considered as the primary key. The next column is department name. Its data type is varchar, which is a character data type. We have provided 50 spaces, and then end of the command. Right? Now comes the insert command. Now, again, similar to table creation, inserting data into a table is also simple and easy. So all you need to do is specify the operation that you want to do. It is insert. I want to insert data, but into which table? So I want to insert into table which is departments that we recently created. You can simply copy and paste the departments table name here. And what are the department columns you have? So I have two columns there. I'll take department ID and department name. And now these are the values I want to insert. What are the values? So again, comma separated values. The first is ID, so you don't have to write any quotes, but the second one is varchar, so character data types must be specified in single quotes. So this is the first entry, comma separated values. The second one is number 2, comma, single quotes, and what's the next one? Maybe engineering, and again a comma separate. And third team could be finance, separate by comma. Fourth team can be marketing. So I don't have any further rows here. So what I can do is I can close this particular indentation. And write a semicolon to explain the end of this particular query. So now, similarly, you can just execute this and add the values. So let's head back to the notepad. So here you go. So this is a similar approach what we have mentioned here on my MySQL workbench. You can follow this indentation so that you are clearer. And you can just simply run the query. I'll use Control Enter, and these values are entered into your table. Now I want to extract what are the values that I have entered into my table, or I want to just cross verify if I have entered all the values or if the values that I have given are properly inserted or not. So for that you want to select. So as we discussed, there are multiple ways to extract data. You can just specify the column names from which table the table is departments, or you can specify dedicated column names. Let's say I want to only extract the department name or department ID. You can also do that. Or another approach for the same code is this one. You don't have to specifically mention the column names. You can just write down an asterisk and it will still execute the same. So let's try all these 4 commands. You have your data here. And the same works for this one as well. Now, let's say I want to select only a dedicated column. So these are your department IDs and dedicated department names. This is your department name. And now, if we drill down further, let's say I want to extract the details for only HR team. So this is where the where clause comes into the picture. So extract or select department name where. So this is basic fundamental queries that I'm really writing right now so that you understand how it actually works in the background. So you understand the workflow of it. So where department ID is equals to, let's run this, department ID 4. So 4 is marketing. So department ID is equals to 4. So what happens is SQL selects the department name column altogether. The entire department column is selected. First, it will go to the departments table itself. It has two columns. One is department ID and a department name. You can see it right here, right? So this particular entire table is selected by SQL. And then it reads what are the columns I need to select. So we are dedicatedly specifying just one column, which is department name. This particular column will be selected in the second phase. The third phase is where it applies the filter for department ID. Now, again, it goes to department ID and it checks individual department numbers. So it will go for the department ID where it matches with number 4 and then adjacent to it is marketing, right? This is what we are trying to extract. SQL has understood this and it will give us the marketing team name. So this is how the query works in the background. Now that we have a basic understanding of how the fundamental keywords in SQL, which are select, from, where, filtering things, right? Basically how to create a table, how to insert values inside a table, and how to query them. Now we will proceed and add a few more tables onto our MySQL workbench so that we can get continued with further queries like some aggregate functions like average, sum, etc. So let's not waste much time. Let's go back to the query window where we have all the table details and copy them and simply write them. So let me copy the entire 3, 4, 5 tables and paste it on the SQL workbench here. I'll minimize this a little so that we have a better view. There you go. So this is our second table, which is employees table. Now, before we create the table, let me explain you a few things. So we have about 5 tables. One is departments, second is employees, third one is users, fourth one is orders, and fifth one is sales. In the terms of data analytics, in the terms of business analytics, we deem these tables as 2 parts. The first one is fact tables and the second one is dimension tables. So what are fact tables and dimension tables? We will deep dive into these in the next upcoming modules. So basically, it's nothing but relationships between the tables. So there will be one table which is related to all other tables in the database, right? So in this particular scenario, the employees table is a fact table and employee is the one which works in your company. Let's say you have an online store and you have a list of employees, and these employees are the ones which receive orders from the users and they fetch your inventory, pack that order and send it to the users, right? So employee table is the fact table which is related to the orders table, which is related to the users table, which is related to the inventory table, which is related to the department table, right? It connects to all the tables. And on the other hand, the dimension tables, these are related to your fact table based on one foreign key, right? You will be having employee ID, right? This particular employee ID will be the primary key of your data table, and somewhere or the other, the employee table will dedicatedly have a department value, department ID, right? It will have the order values, the order ID, it will have the sales ID, right? All these entries will be in the fact table and all these entries will be the primary keys of all the dimension values, right? The dimension tables. These values will connect to the fact tables. So it will be a little confusing now, but when we enter into the data modeling module, there you will have a clearer understanding. For now, let's understand one thing. You just have different types of tables. One is fact table, one is dimension table. Fact table is really important because fact table acts as the mother of all the other tables, and all the other tables are connected to fact table. If you delete the fact table, then there is no way you're going to perform the analytics in future, right? It is like the root. Just understand that basic thing. Now let's continue with table creation. So now let's head back to table number 2, which is our fact table here, or let me tag it as the fact table for reference. Now the same pattern again. We want to create a table. So create command, table command, provide a name to your table, which is employee. And here we have 1, 2, 3, 4, 5, 6 columns. We have employee ID, we have employee name, we have salary, we have department ID, on which date was he or she hired, and the department ID, right? So here we are dedicatedly specifying that department ID is a foreign key which relates this particular fact table to the departments table, and we are referencing this, right? So references is the keyword which helps SQL identify that you are trying to connect this particular employee data with the department data, right? So we have about 5 columns here: employee ID, name, salary, department ID, and hire date. And if you are trying to get this connected with another dimension table, then this particular command where it says we are trying to use department ID as a foreign key, which happens to be the primary key of a dimension table, which is the table name, departments, and in that particular table name, the column name is department ID. It is named as department ID. So please go to the departments table, refer to the department ID column, and then match the entries of department ID from employees table to the department table. So this is how it works. Now let's click the flash logo, or I'll go with my shortcut Control Enter, and we have successfully created the employees table. And similar to the previous approach, you need to specify the keyword insert. I want to perform an insert operation, and I want to insert these elements into is another keyword, and you need to provide the table name, which is employee. And now what are the columns I have in my table? I have employee ID, I have employee name, I have salary, I have department ID, and hire date. So based on the column names, I need to specify the data entries as well. So you cannot mix and match. You are specifically providing the order in which the entry should be happening. So the order is: first comes the employee ID, second comes the employee name, third comes the salary, fourth comes department ID, and fifth is the hire data. In the same fashion, your entries should also be matched. So first, the employee ID is 1, the name is Alice, the salary is 90,000, department ID is 2, so she belongs to department whose ID is 2, right? If we go back to department here and execute this, so we will be having engineering in the department ID 2. So Alice belongs to engineering department, and then comes the hire date, which is this one, right? So you need to specify the data type. So here I have specifically provided the data type as date for hire date. In the same fashion, rest of the employees, employee ID 2, 3, 4, 5, 6, 7, and 8, 9, and 10 are added, right? And deliberately we're also adding some null values here. So you'll understand why we are adding null values, because in future we will be performing some join operations in the upcoming modules where we will try to filter out the employees whose department is not yet allocated. We are considering these employees are new or fresh hires, so they are on bench period and they are not aligned or assigned to any projects as of now. So they are having their department ID as null. So we'll be performing such operations. For now, just try to, here I think I've marked it, no department, right? So for now, just try to create a table and add data. So now your fundamental job to do is you need to understand how to create a new schema, which I've explained before. Go to the schema table here, create new schema, and write a name to your schema, and then apply it to create a new schema, which happens to be a dimension table, and this will be related to the fact table, which is our employees table, right? And here I'll be having user ID, email of the user, and at what time was the account created at timestamp, right? Now Control Enter, and we have created this particular users table. And similarly, we will insert the data into users table. So we will be following the same pattern. So we will be inserting into users table, and these are my values. Let me indent it. So proper indentation will help you understand how your tables are organized. So you can follow this. It might take a little time, but in future it will definitely save a lot of your time entering or making mistakes, right? So this is a good practice or best practice. Now I have about 10 users in my database. And then this is the end of the query. So here you can see I've also tagged as duplicate email entry. So this will be another learning experience for us, where we will try to find out duplicate email entries in our database. Now hit Control Enter. I think we selected employees data table. We were supposed to select users data table. Yeah. Okay, we were supposed to create the data table first. Okay, we have successfully entered the elements into the users table. Now comes our fourth table, which is orders table. Similarly, we have order ID, customer ID, and order date. Control Enter, and we have created the orders table. Let's quickly add all the data into the orders table. You can also follow the same indentation, or if in case if you want to have a particular specific format of indentation, you can also follow that. We have the last table, which is sales table, and similarly let's enter all the data into sales table. Now let's check all the entries or all the tables. The process is simple, like we discussed. Select star from employees. There you go. So these are the employees and their details. And similarly, you can just quickly copy and paste this command and rename this to departments and run a query, and you have all the employees or department details. Similarly, you can copy paste, and then you can use the name of sales, orders, and users. And I'll also have orders, and also I'll have sales. So these are the user details that we have entered, and these are the timestamps when a user account was created, and these are the order details. So these are the orders placed on what detail, on what date, and who was the customer and who was the order ID, and all the details of that. And sales data table, what was the sales ID, on what date was the sale made, and what's the amount they paid, right? So these are the details that we needed. Now let's take a step further and try to extract some details from this particular data set that we have just created. So I'd like to close it here. So far, this is the creation and insert process. Let's comment it. Now let's proceed further, and this would be the querying stage. Now let's try the filtering process. So let's consider we want to filter the details of employees who are earning, let's say 90,000 or more. So how do you extract it? Let's take a moment. So far we have a basic understanding of how to insert data, how to select queries, right? And we also went through a sample where statement where we extracted the marketing ID, right? So the department name where marketing or department ID was equals to 2, right? So following the same approach, can you devise a quick query? Yes, I think you already have a rough template on your mind, but it's okay if you don't have it. So let's get started with it. So as we discussed before, SQL is really simple. All you need to do is just explain SQL in very simple terms. I want to select. select what I want to select. I want to select employee name, or I want to select everything from employee, where from employee, let me copy the employee name to save time. This is the table name from employees, where salary is greater than a rough number 90,000. So before that, let's run this query and see. We have Alice, we have Bob, we have David, we have Eve, we have Heidi, and we have, yeah. So there are a few employees who are drawing salary greater than 90,000. Let's say it as greater than or equal to 90,000. So we must be getting a couple of entries here. So let's quickly run the command, control enter, and there you go. So we have about 1, 2, 3, 4, 5 employees, Bob, Alice, David, Eve, and Heidi, who are withdrawing salary which is greater than or equal to 90,000. So this is one of the good filtering examples. Now let's go with a few other queries or filtering queries. So we have HR, we have employees, we have users, we have sales, we have orders. So let's say I want to extract employees who were recruited after February of 2025. So for that, we can use the same query. We can quickly copy and paste it here from employees where join date, right? So I'll execute the select query once again. So I'll copy this particular field name and paste it here is greater than or equal to March. We don't have a March, but we can take the September. We can copy this particular field and paste it here. There you go. So any employee who is hired after September 2025 should be highlighted. Enter, and there you go. We have about a couple of employees who were recruited after this particular date. Or we can also find out less than who are the employees who were recruited before this particular date. There you go. So only David was the one who was, maybe this can be considered as David is one of the senior most employees in this particular organization. Now let's proceed further and try the next type of query, which is the sorting data. Now I want to sort the employees table. Let's say now I want to identify employees in terms of salary. Who is the employee who is drawing highest salary and who is the employee who is drawing the least salary? I want to order them in decreasing order. So it's really simple. You can use the same query here. Select star from employees and order by salary DESC. So we have two keywords, DESC and ACSC. So ACSC is ascending order, BESC is descending order. So you just need to run this query and we will have salaries of the employees who have highest salary numbers. So we have Bob, David, Heidi, followed by that we have Eve, Alice, etc. And Ivan is the person, maybe he's a fresher, so he's drawing the least intern level salary or the beginner level salary, which is 50,000. And similarly, you can follow another thing here. You might be assuming, can I give 2 columns here? Yes, you can give 2 columns. Order by DEPT. So let's go with department ID. So this even works for character data types as well. Department ID ascending and salary descending. So you need to separate this by a simple comma, and there you go. Enter. Now what happens is, you can organize the department ID in increasing order and organize salary from descending order. So it's just executed for the reason to understand if this particular order by sorting command executes for one or more columns or not. So the reality is it works for one or more columns. So that's the basic understanding. Now we need to understand one more thing, which is filtering out with limits. Let's say I want to find out only one entry which has the highest salary. So in that particular case, what I can do is I can make use of limit command, which limits the number of rows output by one or two, number of, a number, dedicated number. If I just want one entry, I'll have just one entry. In case I want to have top 3 employees, I can provide top 3 as limit 3, and you'll have top 3 rows executed right here for you. So this is where we come across the limit function. And apart from limit, you also have another function which is called as distinct. So the name speaks for itself, unique entries in the row. So for example, let's say I want to find out, let me use the same query, select star from employees, and I'll replace star with distinct department IDs. Copy field name. So what it does is, for understanding what it does, we need to copy this statement and paste it once again, semicolon. Now what's happening is, when you enter this particular query, you have multiple departments. Let's say department number 2, engineering department, is repeated multiple times. But now I don't want to extract all the employee details. I want to just know how many number of unique departments are present in this particular employees table. So in that particular scenario, I need to provide a semicolon to follow the principles or best practices. So here you see we have about, okay, I think for distinct function we might not need semi double quotes. Okay, I think I made a mistake in keyword. Yeah, there you go. We have 1, 2, 3, 4 distinct department IDs and one null. So that is from the employee to which we did not assign any team yet. So that's one thing. And now if we continue ahead, we have aggregate functions, which are basically the average, sum, count, minimum, max, and a few other basic aggregate functions that you use on a daily basis. So for basic aggregate functions, I'll just quickly copy and paste the comments here so that we save time and spend that time for understanding how the query is performing. So here we have the first function, which is counting the number of employees. So basically we'll start with the first aggregate function, which is trying to calculate the total number of count of total employees in this particular data set. So we are using the count function, and here you can provide a dedicated column name, or you can also provide the star logo, which basically calculates the entire rows here. So just enter. Then you have about 10 employees here. Now the next aggregate function is, we will be trying to find out the average salary of an employee from a specific department, which is engineering. So for that, let me expand this again. So for that, first we will be calling the columns from this particular table, which is employees table. And since we are also dealing with a specific department, which is engineering, we need to perform a join operation where we will combine both employees and department tables together based on one keyword or one column, which is department ID. So department ID will be a primary key for department table, and department ID will be a foreign key for employees table. So based on this foreign key, meaning the employees table will be able to get joined or connected with the department table based on this particular department column, department ID column. Now, so our statement is simple. We are selecting average of salary, and we are aliasing it as average engineering salary from the table employees, and we are joining the employees table with the departments table on one common column, which is department ID. Departments dot department ID is equals to employees dot department ID. So departments is the name of the table and employees is the name of the table. So in this particular table, I'm referring this particular column and I'm trying to connect to this particular column in the next table where department name is equals to engineering. Now let's execute this particular query. There you go. So on an average basis, the salary of any employee working in engineering department is 1,08,750. So this is the average salary of any employee who's working in engineering department. Could be more or could be less based on the designation. If he's an intern or a beginner, then the salary might be less. If he's a supervisor or in a senior position, the salary might be more. It's basically an average of both. Now, the next aggregate function that we will be dealing with is the maximum and minimum. So for finding out minimum number, you can use a function in SQL which is called min, and for maximum we can use a function called max in SQL. So it's as simple as that. Minimum of salary as minimum salary, maximum of salary as max salary from employees table. So let's quickly execute this query. There you go. So we found out the minimum salary of any employee in the entire company is 50,000 and the maximum salary in the entire company is 1,20,000. Next comes the last aggregate function in this particular domain, which is count function. So we will be selecting a department ID and we will be counting the total number of employees per department, and we will also name it as employee count from the table employees, and we will be grouping it by department ID. Let's enter. There you go. So we have one employee who has no department assigned, maybe he's an intern, and department ID 1 has 2 employees, department ID 2 has 4 employees, department ID 3 has 1 employee, and department ID 4 has 2 employees in it. And with that, we have come to an end of this module, and we have understood the basic functionalities on how to create a table, how to insert a table, how to select or extract data entries from a table, how to filter data using where clause and having clause, and we also learned grouping, aggregate functions, basically all the fundamentals to proceed with the upcoming modules. And with that, we transition to the next module. So now we enter module number 3, which is about understanding SQL data types and operators. This particular module will help you set the stage for all the basics. In this module, we will be diving into something absolutely fundamental, something every single SQL developer, data analyst, and database engineer uses every single day: data types and operators. Now, I know what you're thinking. Data types? Operators? Isn't that basic stuff? Yes, it is basic. But it is also the reason behind almost 70% of SQL mistakes that beginners make. Wrong data type breaks queries, slows down performance, and causes corrupted results, and even sometimes crash the entire production system. I've seen senior developers accidentally storing dates as text and then wonder why the database can't sort December properly. So in today's chapter, it's not just theory, it's how not to break your job interview or your database. Let's dive into this section. The first step is understanding SQL data types. Before we even start to write a single query, SQL forces us to follow this one golden rule. Every piece of data must have a type. Why? Think of a database as a massive warehouse. Data types are the labels on the boxes. Without labels, the warehouse becomes chaos. With accurate labels, everything is fast, searchable, optimized. SQL databases rely heavily on the data types for storage, indexing, comparison, sorting, and performance tuning. Imagine a library where books have no categories. SQL without data types feels exactly like that. Now let's break them down. First one, numeric data types. We have integer, or it is also specified as int, which is used for whole numbers. Great for IDs, counts, quantities. For example, age can be stored as integer. Product ID can also be stored as integer. Quantity, the number of items ordered. Now, it's a small story type. In one of my early projects, someone stored product prices as int field. So the price was $99.5 or 99.5 rupees. So the total became 99, ignoring the 50, right? Or the decimal value. Now, what happened because of it? We lost precision and the entire billing report was off by lakhs. Lessons learned: use the right data type. Now the right data type was numeric type or a decimal one. So this is the superstar for financial data. P is equals to precision, total of digits, and S is equals to scale, which is digits after decimal. Now for a simple example, consider this one. Decimal 10, 2, up to 10 digits and 2 digits after decimal. The maximum value is 99 millions dot 99 decimal values, or one decimal value less than 100 million. Now, real world use case: salaries, prices, taxes, rates, weight, percentages, etc. Next comes the float or double data type. It is used when you need very large or very small numbers, but some precision may be lost. Think scientific data sensors, machine learning scores. But don't use float for money unless you want rounding problems or angry accountants calling you. Now the next data type is character data types. We have char function n for fixed length string. Always use the full allocated space. Let's consider country codes where you have some country codes for that. For India, you have IN for US, you have US, and you can also have gender, which we have M and F. For example, country code, character data type, 2 values. And the second one is varchar, and it is one of the most commonly used ones. It stores variable length data, and some of the use cases to consider as names, emails, city names, product descriptions, etc. A small story again. Once I saw a table with varchar and the limit was 5,000 for storing the first names. First names alone. Imagine allocating 5,000 characters for storing just a 3-letter word like Max or Raj. Now, what are the lessons learned here? Proper sizing matters for performance. If you store 5,000 characters for just 3 letters, your space is wasted. And this might affect your performance. Now, the next data type is text. Text is used for large bodies of text. Blogs, descriptions, comments are a few examples. But avoid text whenever a reasonable varchar works in place of text. It cannot be indexed efficiently. That's the problem. Now, the next one is date and time data types. SQL is amazing at working with time-based data, but only when the data is stored correctly. For example, dates are stored only in year, month, and date types. You can see on my screen, we have YY, YY, MM, and DD as the format. This type of formatting is perfect for birth dates, join dates, attendance logs, and a lot more. Next is time, and time stores only time. And after that, we have date along with time function. This can be represented as date time together or also known as time stamp. This stores date along with the time. Now some of the use cases: timestamps, log entries, attendance tracking, transactions. A mistake I've seen too often is people store date time as varchar, right? A data type change completely. And then sorting goes like 2024 1-1 or 2023 12-1, 2024 1-10. Completely messed up, right? Now, this can be solved. You just have to change the data type, and also we'll go through some examples in the real-time use case where these type of issues are addressed. Moving ahead, we have the Boolean data types. So the name stands for itself. It is either true or false. Some of the examples is active, is verified, is published. Never store Booleans as varchar. You might be wondering, why cannot we use varchar? It is just simple yes or no. Reason: if you use varchar, it wastes space and breaks the filtering logic. That's the main problem. Proceeding ahead, we have the next data type, which is binary, and miscellaneous data types, which is blob. This particular data type is used for storing images, PDFs, videos, JSON files, and they store semi-structured data. Modern SQL feature: JSON is a lifesaver when you need flexibility without completely switching to NoSQL. Now let's go to the next section where it will help us to learn the arithmetic operators and other functionalities. Operators help us calculate, compare, and manipulate data. Let's start with the easy ones. The first one is arithmetic operators. Just like math operator, operator meaning example, addition salary plus bonus, subtraction price, discount, multiplication, quantify, and division, modulus, etc. Now let's go through a simple example query. So you can see it on my screen. Select product name, sales, quantity into rate as new sales from Excel data. Now the real-time analogy. Operators like these are calculator inside SQL. Instead of exporting data into SQL, SQL helps you compute right inside the database. Now let's also go through a real world scenario. Imagine a store wants to compute total revenue, discounts, tax calculations, profits instead of running separate scripts. A single SQL query can handle all of these arithmetic operations. Now let's dive into section 3, logical operators. Logical operators help SQL make decisions like, should this row be included? Does it match with condition? Is it true or false? Followed by that, we have AND operator. All conditions must be true. For example, where salary is greater than 50,000 and department is engineering. You can see that query right on my screen. Followed by AND, we have OR operator. Any of one condition should be true, where city is equals to Mumbai or city is equals to Delhi. So this selects all the entries from the cities of Mumbai and Delhi. You can see a sample query on my screen. Followed by that, we have NOT operator. This exactly reverses the condition, where NOT country is equals to India, and this particular query is on my screen. So you can see any other data apart from India. Logical operators like filters on YouTube, language is equals to English, duration less than 10 minutes, category is equals to technology. SQL just filters rows instead of videos. Now we land into section 4. So this particular one is based on between, in, and like operators. Sometimes we have another one as well, which is called I like, which is the opposite of like. These are the operators you will use every single day. Now another one is between operator. So this is used for ranges. For example, columns between value 1 and 2. For example, you can see it on my screen. Select everything from Excel data where row ID is between 10 to 20 or 10 and 20. Now what this query does is it will eliminate any rows before 10 and it will eliminate any rows after 20. Only the rows between 10 and 20 are executed and shown to you. Now a friendly tip. Between is inclusive. It includes both the boundaries, which means 10 and 20 are included. They are not excluded. Now let's dive into the next one, which is in operator. Instead of writing many OR conditions, you can just write one in condition and write the set of cities. For example, you might want 3 or 4 cities. So what you can do is where city is in and the function, inside that function, you can write the city names. For example, Mumbai, Delhi, Hyderabad, Bangalore, and many more, right? Whenever a city name matches with the elements present inside the in function, that particular row entity will be selected and displayed for you or filtered and displayed for you. Now followed by that, we have like operator and pattern matching. So you'll have a modulus sign or wildcard which represents any number of characters, and the example is right on my screen, where name is equals to or name like modulus a and ends with a where name like modulus sign an modulus sign, so contains an as a wildcard. So any name which has an included in it, and it might have anything in front of it, it might have anything in the right hand side of it or the end of it. So whichever text has an inside it, all those text values will be extracted and displayed for you. Now in the section 5, we will have a small practical story or a real world analogy. To make this chapter sticky to your memory, let's run through a few stories. The first one, date disaster. An HR system stored join date as varchar. So sorting by join date gave Jan 10, Jan 2, Jan 25, Jan 5. Why? String sorting treats 10 as smaller than 2. Solution: convert varchar to date to fix everything instantly. Moral: always pick the right data type. Let's also go through story number 2. The like operator that saved a scale. An e-commerce company needed to find all products with Pro in their name. iPhone Pro, MacBook Pro, GoPro. One more simple query where product name like modulus sign Pro modulus sign. It can have anything before Pro, it can have anything right hand side of or the end of the Pro. So basically any text which has Pro included in it will be displayed. So what's the result? Marketing team recovered thousands of lost sales because these products were mistagged. Now comes the section 6 where we will have some demos. Here are some fully explained queries for learning purposes. So we will be diving into MySQL Workbench and start executing commands. So now we are on MySQL Workbench for running all the examples that we discussed previously. So my data is in sample database. So we will be using the use database keyword. Let me expand the screen. And the name of the database is sample. So we are in a sample database right now. And we have to show the tables that we have. Again, the keyword. You can see that MySQL Workbench is showing us some recommendations, but we don't want any recommendations. We should go with what we have. Now, apart from that, we want to see what's inside this particular table. So, yeah, Superstore. So we were supposed to go into Superstore, not a problem. So this is our database name and show tables. We have checkpoint data, we have complex post view, and this is the Excel data we need to work with. So now let's type a command, select star or everything from Excel data, so that we have an information on all the rows and columns that we have to deal with in this particular execution. So we have row ID, order ID, date, shipment date, customer ID, and everything that we need to know. So now we will execute some sample queries to understand the functionality. So let me write down the demos that we want to execute. So the first demo is about finding employees earning between 50,000 to 100,000. Right, this is the first query. Let's leave a little space and also write down demo 2. And what's about the demo 2? We need to search city names. So these are the examples that we discussed before on the go, right? So containing PUR. So it can be Nagpur or any city which has the letter PUR in it. So it took an auto recommendation, or instead of PUR you can also have anything like DEL, right? So now let's go with the third demo, which is show products with price calculation. And demo 4 will be about list users from specific cities. Demo 5 will be about employees not in HR department. Or we can also make some changes to this based on the dataset that we are working with. So we can go ahead with the segment here. We have segment in, we have which are not in segments of consumer or anything apart from consumer and home office. In specific segment, let's go with the consumer. And lastly, demo 6, which is about items with exactly matching some words, like let's say OUR, or let's say instead of exactly matching, we can consider this as text matching. So we have a template or a skeleton of what demos are we trying to execute here. Now let's start with queries. Now I want to find out any employee or any of the products. So we have number of pricing, right? So we should go with sales here. So let's identify sales which are more than 3,500. So between 3,500 to 4,000, or sales, find sales between. So this is a requirement. So what we will write is a simple select statement. We will select everything or select a specific product name. So we will go with the product name. So what I'll do is I'll simply copy this field name. I'll paste it over here, comma. I want sales column as well from Excel data. Where sales is between $35 and $4,000. Now we have the list of products that are having this range of sales. So we have about 5 or 6 entries which have the sales in between 3,500 INR or dollars to 4,000 INR or dollars. And now let's go into the demonstration 2 where we wanted to find out city names containing PUR. So if we go back to our Excel data set, we had a column which had the address, right? So we had cities like Leeds and a few other things, Paris, Parla, and all those things. So I want to find out any city name which has some given text. For example, if you go with Munich, so we have MUNICH, right? And we have Naples here. So APL or APL. So any state or any city which has Hamburg, etc., right? So any state which has AMB, I want to extract it, right? So let's write down a query for that. Select city from Excel data where city like, since we're using a keyword, let's have like, and since this is a text related data, we need to encode in between single quotes and we want Hamburg, right? So AMB and anything after AMB, semicolon, enter. So now we have any city which has AMB included in it displayed here. We had Cambridge, we had Hamburg, and all those city names which has AMB included in the text. Now let's go with the demo 2. We wanted to show the price calculations. So we have, let's execute this one more time. So we already have sales data, right? So if we go back here, let me scroll it. So if we go back here, we have the rate of every single product and the number of quantity. So the rate for single unit was $24.4 or rupees, and multiplied by 3 times, you have 79.2 as the final price, right? And now I want to calculate that once again. Let's say we didn't have that sales tag or sales column. If we wanted to calculate it, how would you do that? That's the problem, right? So we can do this by the following application of the formula. So what you can do is write down, select. What we want is product name. So I'll just copy paste this particular field name here instead to avoid any kind of errors. Comma. We also have sales, right? So let's keep sales, comma. We have quantity star. Let me copy that. Quantity into price. We have rate here, so we'll copy this rate name, paste it here, and we'll alias this as new sales from Excel data, semicolon, enter. So now we have all the product names and the sales and new sales. Remember the one which we discussed, decimal points. So we did not, kind of constraint to, minimize the number of decimal points. So it gave the full potential of decimal points here. So we could, include a new column with mathematical or arithmetic calculations to go ahead with. Now the next demonstration was about including all the details about a specific segment. So list users or list products. So what we can do is, again, a simple select statement, star from Excel data,
where
segment in. So we want the following. So we have segment as corporate, we have consumer, right? So I want, let's say, corporate and consumer, comma, consumer. So since these are text-based data, so we need to include single quotes as well. And a semicolon to close the data. And there you go. So we have also, you can choose to include only a specific segment, but overall we have filtered the data to include only corporate and consumer related data set. Now, if we go into fifth, so data of the not in segment, so all you need to do is a simple change. So you can copy this and paste it over here as it is, and simply replace in with not in, and there you go. Now you'll get all the data which is not from the section of corporate and consumer. Run that, yeah, there you go. Okay, there was a small error mistake, corporate, and we could also include corporate, separate by comma. There you go. Now let's execute this command. And now we only have a home and office depot related data segment. So that's how you can filter. And the last one is nothing but text matching. So where we wanted to find out the products which have this particular, naming convention. So it's similar to this one which we executed before. Select city names which have this following text matching. So instead of AMG, you can go ahead with any of the other city names like MIL or ILA. So you'll have any of the cities which have ILA in that. This is the list of the cities. And now with that, let's close this particular section with pro tips and best practices. So let's wrap it up with some practical wisdom. First, never store dates as VCAP. This is the number one beginner's mistake. Use decimal for money, not float. Float introduces rounding errors. Third one, keep VCAP length realistic. Avoid VCAP 5000 unless necessary. Next one is use in for clearer queries instead of many ors. Fifth one is like with leading wildcard, and it is slow. Avoid it in large tables. Sixth one is Boolean fields, make filtering faster and cleaner. Seventh one is use int for IDs fields, not VCAP. Eighth one is understand indexes before using like frequently. And the final summary. In this chapter, you learned why data types matter more than most people think, how numeric, character, datetime, Boolean, and advanced types work, how arithmetic and logical operators really behave, how between, in, like help simplify filtering, real stories that highlight how crucial good data modeling is. Now let's also go through some professional best practices you can use immediately. With this foundation, you're now ready to write cleaner queries, avoid common mistakes, and handle real-world SQL tasks confidently. In the next chapter, we will start leveling up with constraints and advanced filtering logic, which is where SQL begins to feel powerful. Stay tuned and keep practicing. Module 4, Safe Deletion Practices and Best Practices for Data Entry in SQL. Before we talk about writing advanced queries, joins, or analytics dashboards, there's one uncomfortable truth every SQL professional must understand. The most dangerous SQL queries are not the complex ones. They're the simple queries executed without thinking. And among all SQL commands, there's one command that has probably caused more panic, data loss, and late night emergency calls than any other. And that command is delete. In this chapter, we are going to slow down and talk about something that separates beginner from a professional. It's basically depends on how you delete data safely, responsibly, and confidently, and how you insert and maintain clean, reliable data from day one. Because in real world, SQL is not about writing queries that work. It's about writing queries that don't break business. So the part one, why delete statements are the most dangerous ones. So let's start with a very honest question. Why is delete such a scary command? The answer, delete is permanent. Delete does not ask for confirmation. Delete executes immediately. Delete can affect millions of rows within mere seconds. There is no undo button in SQL for delete option. Once data is deleted, reports break, dashboards go blank, finance numbers change, trust is lost. And most importantly, you are accountable. That's why companies don't fear complex joins. They fear one command, that is careless delete statements. Now, with that, we enter into part two, the most common delete mistakes that a beginner makes. So let me share you the most common and most dangerous mistakes beginners often make. Let's look at a sample on my screen. For your information, we are not manipulating this database as of now, because we will be using these tables for our next module, and if we run these commands and delete or truncate the data, then we might lose it and we might have to recreate again. So let's not do that. Let's have a sample query on my screen, and that should be good enough for you to understand what's the flow. So here's the query: delete from employees. We are deleting from the employees table. That's it. No where clause, no filter, no condition. This query means delete every single record from the employees table. In a production system, this could mean all employees' records are gone, payroll reports destroyed, compliance violations, audit failures, and here's the scary part. SQL will happily execute this query. It won't warn you, it won't ask you, it will just do it. This is why experienced SQL professionals treat delete like handling a loaded weapon. And with that, we transition to the part three, safe deletion principles. So the first one, always preview before delete. The golden rule of safe deletion is simple. If you cannot select it safely, you should never delete it. Before deleting anything, always run a select query using the exact same where condition. Step number one, preview the data. Let's take a look at the simple query on my screen. Select star from table, that is employees table, where department is null. This should show you employees without a department. Now ask yourself, does this data look correct? Are these the records I truly want to remove? Is this count reasonable? Only when you're 100% confident, move to the delete option and delete those records. Now comes the step number two, convert select into delete. Let's look at the sample query right on my screen. Delete from employees where department ID is equals to null or is null. Same condition, same logic, no surprises. This single habit can prevent 90% of data deletion disasters. Now with that, we transition to part number four, safe deletion principle number two. Use transactions. This is professional level practice. In professional environments, delete is rarely executed alone. It is wrapped inside a transaction process. A transaction allows you to preview changes, validate row count, roll back if something looks wrong. For an example, safe deletion using transaction. Let's take a look at this sample code on my screen. Start transaction, semicolon, delete from orders where order date is less than 2025, 1st of January. Now, select row count method and then roll back. What's happening here? SQL prepares the deletion. You check how many number of rows would be affected. If the number looks wrong, you can directly cancel it. When you're confident, then you can commit. This is how real companies delete data. If you mention transactions during your interviews, it instantly signals production level experience. With that, we make a transition to part number 5 of this module. Safe deletion principle number 3. Delete with primary keys when possible. So what do you mean by primary key based deletion? Never delete data using wait conditions if a primary key is already available. So what could be the dangerous part? Let's look at a sample code on my screen. The code will be delete from users where email is equals to alice@example.com, right? Now, how would this be dangerous? Let's say you have orders data and Alice is your company's employee. Alice might have made thousands of sales and she might have entered the same email ID, which is alice@example.com. When you run this query, those thousands of orders records will be vanished in a mere second. Let's say you wanted to just delete the order for a specific number, let's say order 123, and instead of order 123, thousands of all other records based on alice@example.com will be deleted. So now let's understand why this is risky. So in technical terms or SQL terms, email may not be unique. Remember the unique keys that we discussed? You might delete multiple records unintentionally. Now what's the safe process to escape this? Let's look at the sample code on my screen. Delete from users where user ID is equals to 4, right? Or order ID is equals to 4. Now this will be the safest step. It will only eliminate the records of that particular primary key. Now let's go with primary key. Primary keys are unique, they are predictable, they reduce accidental data loss. Professionals think in keys, not names. Now with that, let's make a transition to part number 6 of this module. Safe deletion principle 4. Soft delete. This is again an industry standard. In many real systems, data is never permanently deleted. Instead, companies use something called soft delete. So what is soft delete? Instead of removing the record, you mark it as inactive, you preserve history, you avoid compliance issues. Example, add a status column. Let's look at the sample on my screen. Alter table users, add column, is underscore deleted, boolean default false. So what's happening here? You're trying to make some changes to the table users and you're trying to add a new column which is termed as is deleted. And you're adding a new boolean value which is by default false. So in case if you're trying to delete something, then you will refer to this particular default false value, and anything if you want to hide or delete or filter, you can just use that command and filter out those rules. That's what is happening here, and that's called the soft delete option. Now the soft delete query. Let's look at the sample on my screen. Update users, set is deleted is equals to true where user ID is equals to 4. Now the next one, fetch only active records. So for that, let's look at a sample on my screen. Select star from users where is deleted is equals to false. Now why companies love soft delete? It is audit friendly, reversible, safer, analytics friendly. If you say soft delete strategy in interviews, it shows maturity. Now let's make a transition to part number 7, delete versus truncate. It's an important distinction. Many beginners confuse delete and truncate. So let's discuss this once. Let's start with delete. Delete can use where. It can be rolled back when used with transactions. It triggers logs. It's slower but safer. While truncate, on the other hand, deletes everything. It cannot use where clause. It cannot be rolled back. It's extremely fast and extremely dangerous. So let's have this rule of thumb. If you don't fully understand truncate, don't use it. With that, let's make a transition to part number 8 of this module, which is about best practices for data entry. It's the foundation of trusted analytics. Now, let's shift gears. Safe deletion protects your data. Good data entry prevents problems before they even exist. Bad data is more dangerous than missing data. So, the best practices. Number 1. Always define data types correctly. Every column should reflect real-world meaning. Let's go for an example for bad design. Salary, worker, 50. So you know this is a character data type and it doesn't make any sense. The correct way, salary is integer or salary float. Why this matters? Sorting works correctly, aggregations are accurate, performance improves, data validation becomes automatic. SQL data types are your first line of defense. Now, the second best practice, use constraints, not trust. Never trust users, applications, or APIs to send clean data. Use constraints. So the first one, primary key. Primary key is employee ID in our case, a foreign key. department ID, which can reference department ID from the other table. And for safe side, you can also keep another constraint which says not null. So whenever a null value is being trying to insert, it will not take it. It will definitely throw an error. Next one is name, workcar 50, and it can also be not null. Unique value, which is email, workcar 100, and it should be unique. And another few benefits of using constraints: it prevents duplicates, maintains relationships, stops bad data early. Good SQL developers design defensively. And with that, the next best practice, that is number 3, handle null values intentionally. Null is not bad. Unplanned null is bad. Ask these questions. Is null allowed? What does null mean in business terms? Should there be a default value? For example, department ID data type is int and null, meaning employee may not belong to any department. This is acceptable only if business allows it. Clarity beats assumptions. Now with that, the next best practice, number 4, insert only verified data. Before inserting data, validate the formats, check references, confirm business logic. Let's look at a sample on my screen. Insert into employees, employee ID, name, salary, department ID, hire date. Select 11, Kevin, 80,000, 2, 25, 12, 10. Where exists, select 1 from departments where department ID is equals to 2. This is a sample query on my screen. This ensures 2 things: department exists and referential integrity remains intact. Now the best practice number 5, standardized data formats. Inconsistent data kills analytics. Bad HR, human resources are a good example for that. Now, good version of it: single standardized value. Solution: use lookup tables, enforce values via foreign keys, avoid free text whenever possible. Now, clean data is equals to reliable insights. Now, with that, we have best practice number 6, log changes for critical tables. In real systems, every insert, every update, every delete is logged. Why? Because audits, debugging, compliance, accountability. This is why data engineering and SQL governance matters. Now, you might be wondering why this chapter matters. Let's look at the summary. Let's close this with something important. Anyone can write SQL query. Anyone can join tables, but only responsible SQL professionals delete data safely, protect data integrity, design clean schemas, think long term. Companies don't trust databases to beginners. They trust them to people who respect data. If you master safe deletion and data entry best practices, you are no longer just learning SQL. You are learning how real systems survive. In the next module, we will move into joins and relationships using the same database to answer real business questions. Real-world data never lives in a single table. In real companies, employee names are in one table, department names are in another, orders are stored separately, revenue lives somewhere else. If you know how to query one table at a time, you don't know SQL. You know toy SQL. The moment SQL becomes powerful is when you learn joins. Because joins are how HR teams combine employees with different teams, finance teams combine orders with revenue, product teams combine users and behavior, analysts answer business questions, not just technical ones. This chapter is where SQL stops being syntax and starts becoming decision making. Why joins exist is your next question. Let's take a step back and understand why joins even exist. When databases are designed properly, data is normalized, redundancy is avoided, each table has a single responsibility. For example, employees table. Employees table only stores employee details. Department table stores only department names and other details related to department alone. We don't repeat department names inside employees. So, why is this done is your next question again. It is done for few reasons. One is data consistency, easier updates, better performance. But this creates a challenge. If data is split across tables, how do we see the full picture? Right? That's your question now. That's where joins come into the picture. A join tells SQL, combine rows from 2 or more tables based on a relationship. And that relationship is usually a primary key in one table, a foreign key from another. In our database, department.department ID is the primary key from department and department ID from employees is the foreign key for employees data table. This is not accidental. This is an intentional design. What's the business analogy behind it? It's very important for learners. Think of joins like VLOOKUPs on steroids. But unlike Excel, joins scale to millions of rows, joins preserve data integrity, joins power dashboards, reports, and even AI systems. If select is asking a question, join is asking a smarter question. Now, let's go to MySQL Workbench to execute some of the queries on joins to understand them even more. So now we have discussed the theory part of module 5. Now we will be proceeding into the demo part. Here we are going to slow down things a little bit because joins are not about memorizing syntax. They're about understanding how rows from different tables come together and work together. Most SQL learners struggle with joins because they imagine tables merging physically, data being copied. That's not what happens. A join is a logical operation, not a physical one. So in this session, we will visualize tables row by row. We will see which row survives, which rows disappear, and why that is happening. By the end of this module, inner join will feel more obvious. Left and right join will stop being so confusing, and full outer join will finally make some sense. And you will understand joins well enough to explain them to someone else. That's a real goal. Now, let's start with first query, employees with department names. Let's have a look on the query on my screen. So you can see, let me minimize this output window. So you can see we are starting with the demos of module 5 from here. To get access to the data table inside this particular database, we will be executing use interview, which is the schema name. And now we are on the first type of demonstration here, first query. So what is the first type of join are we executing? So the first join we are executing will be an inner join. But before we understand what exactly or technicality of this particular join, let's understand the problem that we are solving. So we have an employees table. We have another table which is departments table. And we already know what are the columns. We have an employee table and department table. So now what is our end output for this particular query, or what's the business question? Employees store only department ID, not the department name. So the business question here is, show me employees along with their department names. This is a classic relational problem. So let's deal with this in a step-by-step way. Step 1, understanding the join condition. So the join condition here is specifically mentioned. Department ID from employee table with department ID from the department table. This line defines how rows are matched. It tells the database, take department ID from the employees, match it with the department ID of the departments table. Only rows where this condition is true will be joined. Remember, this condition is not filtering after the join. It is defining the join itself. That distinction is critical. Now, let's go into the step number 2. What inner join really means? Inner join means only keep the rows where the match exists on both sides. So, employee with a valid department is kept and employee with null department will be removed. So, remember the employee with no department in the employees table? So, that particular employee will not be considered here. Department with no employees will also be ignored. So, we might be having certain departments in the department table with no employees. So, that will also be ignored. Think of it as, give me only the confirmed relationships, not any vague relationships. Row by row visualization. Imagine looping through employees. Alice is equals to department ID is equals to number 2. And engineering exists is equals to keep. Bob from department ID 2, which is engineering, exists, so keep it. Charlie from department ID number 1 is from HR and it exists, so keep it. And lastly, Frank, the department ID is equals to null and no matches found, so that will be deleted. Frank completely disappears from the end result. That's how inner join behaves. Now, let's select the entire query and execute. So as we discussed, there are 2 different ways to execute. So let's go with the shortcut Control Enter to execute the command, or you can also go with this flash logo here. So you can have the output table right here. So the department or employee ID, employee name, his salary, and department name. Second one is Ivan from employee ID 9, salary and department name, which is HR, and so on. We have about a couple of entries here. So overall, where the department is not null and employee is not null, those particular specific columns have a relationship established successfully and those will be combined or joined together, and we have an end output here. We can also name this as, instead of specific name, ID, salary, department, you can also keep star, where all the columns of both tables will be displayed all together. Let's try that for a homework. Now, from an interviewer's perspective, interview insight, if someone asks you, why is Frank's missing? Your answer should be, because we applied inner join. Inner join only returns rows where the join condition succeeds on both the tables. That shows clarity. Now let's move to the next query. So let me scroll down my query, and here we will be implementing left join. All employees without departments. So let's have a look at the query on my screen. So this is the one which we will be executing for left join. Key mindset that you should be having in your mind is, what exactly is left join? The left join means the left table is mandatory, the right table is optional. Whatever happens, every row from the employees must appear, even if there is no matching from the department table, which happens to be the second table. What changes did you find here compared to inner join? It is only one thing. Rows without a match are not removed here. Instead, missing columns become null. Let's have a visual walkthrough. Let's focus back on Frank again, where Frank did not have any department ID. It was basically null. So no department match. But left join always says keep him anyway. That's the main core difference between the left join and inner join. So now let's see the result. So before executing the query, let's find out how it may look like. So employee ID is equals to Frank's ID, name is equals to Frank, and salary is Frank's salary, and department will be null. It is intentional, null. It's not a bad data. Now, let's execute the query and see the output. So let me select the entire query and hit enter, and there you go. So we have Alice, Bob, Charlie, David, Eve, and here you can see we already have employee ID 6, Frank, Frank's salary, and Frank's department name is null, right? So even if the matches are not accurate, right, in terms of accuracy, even if there is no actual match between both the tables, but whatever the data we have in the left table, which is employees table, everything will be present. That's the major difference between inner join and left join. Now, even if this kind of data is existing, why companies or why professionals prefer left join is your question. Left join is used often when you want to complete coverage, when you want to detect missing relationships, you want to preserve the main data set. When you have these kind of intentions in your mind while executing query, then left join is the most preferable one. So what are the kind of examples you must be thinking when you are dealing with left joins? So all users, if they are never ordered, all products, even if they are not sold, all employees, if they are not even assigned to a dedicated group like Frank here, right? So these are the scenarios where you are forced to use left join. Now a quick interview tip, a powerful phrase. Left join preserves the left table cardinality. That's senior level language. Now let's go into the next query. So the next query will be based on right join. So let me highlight my query first. And now let's understand the technicality. So this particular query is based on all departments, even if no employees. Let's take a look at the query on my screen. So conceptual identity to the left join. Right join is just the left join from an opposite direction. Previously, we focused solely on the left table. Now we will solely focus on the right table. Now departments are very mandatory. Employees are optional. In the previous one, employees were mandatory and departments were optional. Now this is the opposite side. What row survives will be your question. Departments with employees and matched rows will appear, and also departments with no employees will also appear. But anyways, employees without departments is a little bit irrelevant here, but for the concern of understanding, let's keep it that way. Now, let's execute the query to understand the output. Now, there you go. We have all the departments and their employees together. We have HR and the name of employee is Charlie. We have Ivan from HR, and we have Alice, Bob, and David from engineering, Heidi, Eve from finance, Grace from marketing, and Judy from marketing. Now, let's understand one more thing. Why right join is rarely used. Most developers prefer left join, reorder table instead of using right join. So, this query could be written as from departments D, left join, employees E, right? This is also a perfect logic. Same logic actually, more readable. Now, for that, let's have a small teaching insight. Right join is important to understand. but not commonly used in production code. Now let's dive into the fourth query, which is about a simulated full outer join. So why simulated, you ask? Because there is nothing called full outer join, but we can still have a simulation of it by including the union in our code. So you can see I have highlighted the code and we have a union command here where we will combine both the tables together. So now why are we doing this? Some databases do not support full outer join, or learners want to understand how it works internally. So for that we have a query highlighted right on my screen. We'll simulate it. But before that, what full outer join means conceptually? Give me everything, right? This particular data extractions include matched rows, left only rows, and right only rows. Basically, what we are trying to do is we are combining inner join, left join, and right join, basically extracting whatever is present inside both the tables. Nothing is lost. And now you might be having a question. Why did we use union here? Left join keeps all the employees from left. Right join keeps all the employees from right, basically employees and departments. And what is the purpose of union is union combines both and removes any duplicates present in both the tables. So what's the result? Full coverage from both sides. Now let's execute this query and see the output. So there you go. We have all the names of the employees and their specific departments, similar to the previous query. So we have Frank without department name, and all the other employees with their dedicated department names right here. Now, what's the important learning moment? This query teaches join logic, set operations, result set thinking. This is advanced understanding, not beginner syntax. Now, let's move with a few example queries. So first one, I want to identify orders with user email, and we could go with an inner join here. So let me select the entire query. Now let's understand the flow of this particular query. So take a look on my query at my screen. Business story orders store, and we have customer ID, not customer email. User store, and we have email, not every other details on that, right? Now we want to join to enrich the order data. Why inner join? Because inner join makes sense here. An order must belong to a user. So orders without users is invalid. Inner join enforces data integrity logically. So before we move further, let's execute this command and see the output. So we have order ID, email ID, and order date as per our requirement. Now, what's the real world relevance? This is how dashboards, invoices, analytics queries are built. Almost every real system uses this pattern. Now, let's go with the next query where we will try to find out revenue per order date. And we will be using an aggregate function here. So let's take a look at the query on my screen. So shift in thinking. We are no longer looking at rows. We are looking at groups of data. Group by in my query changes everything. How group by works conceptually and everything else. Now, let's look at the database steps. First, we will scan all the rows. Then group by order table, plus we will also be applying an aggregate function per the group. And then we will return one row per group. So let's quickly execute this query and see the output. There you go. We have order date, total number of transactions, and total revenue all in one shot here. So why count and sum work here? Because count of number of rows per date, and sum adds revenue per date. This is basically time series analysis, and it is extremely common. Now a quick interview insight for you. Group by reduces number of rows. Join expands number of rows. Remember that contrast. Now we have query number 7, which is about employees with highest salaries. And here we will be using two things. First is a join function, and next is a filter function. Now let's take a look on the query. So here we have employees with highest salaries, and this is my query. So what we are basically trying to do is we are combining both the tables, which is employee table and departments table, and our concern is to find out any employee whose salary is more than 90,000. So that's the overall observation on this particular question or business question. So what's the execution order? Coming to execution order, one of the most important and commonly asked question in SQL interviews is the execution order of the commands. So far, we have seen through all the basic fundamentals of SQL commands, right? The keywords basically select, join, and all those things. So let's consider this as a homework. Let us know in the comment section below what is the execution order of all these keywords in SQL. Now, for a quick clue, let's see the flow of execution for this particular query. So what happens is, first, Join is the one which activates. It joins both the tables. Then where comes into the picture? It filters the rows. And then comes selects, which formats the output. And this order matters. Let's quickly execute this query and see the output. So there you go. We have Bob, David, Even, Heidi, who have salaries greater than 90,000 and their dedicated departments are engineering, finance. So these three employees are from engineering department, and we already discussed this, right? Engineering department is the one which is paying highest number of salaries. So we have three from engineering itself, and the next one is finance. Now, why where is executing after join? This is your question, right? We are filtering employees, not departments. If we filtered earlier, we might lose the relationship context. Now, let's have a quick practical takeaway. Join defines relationships, where it defines conditions. Never confuse with both of these. Now we have the query number 8, where we will find out departments with no employees at all. Now, let's take a quick look on the query on my screen. So this is my query. I want to select the department name from departments B, and I want to apply left join, and I'm joining this with employees on the category of department ID, and where employee ID is null. This is a classic interview query and it tests deep join understanding. What's happening is, in a step-by-step way, left join keeps all the entries from the departments table where employee ID is equals to null, and it keeps only rows where no employee is matched. So the result, let's execute this to find the result. So there you go. Departments with 0 employees. Why inner join can't solve this? Inner join removes non-matching entries. Left join plus null, check, reveals them. This is powerful logic. Now we move into the 9th query, customers with multiple orders. So let's take a quick look on the query. Now this is a multi-layer query and it combines a lot of things. For example, join, group by, and having. This is real-world SQL. Why having is used instead of where could be one question in your mind, because where filters rows and having filters groups. This you need to understand. This is one golden rule which you always need to keep in your mind. Now let's discuss the execution logic. Join users and orders. Join is used to combine users and orders. Group by to group or categorize email. Count is used to count the number of orders per user. And lastly, having keeps only the users with order numbers greater than 2. Now let's execute this query. So we have the output here. We have Alice and Bob with total orders 4 each. That's the output. Now what's the business meaning? This query finds out the loyal customers, high engagement users, retention targets. Exactly what analytics teams do on a daily basis. Now this is a final wrap up for joins. If you understand this module deeply, joins are no longer scary. Nulls make sense. Aggregations feel logical. Interview questions become more predictable. You didn't just learn the syntax. You learned how databases combine data, how SQL thinks, how real systems are queried. That's professional level SQL. And with that, we make a transition to the next module. Now, repeat. Now we have reached to the module number 6, which is about grouping and aggregating data in SQL. So here we will be dealing with group by, having, aggregation functions, and filtering group results. Now let's have a quick introduction to this. Why this chapter or this module matters the most. Up until now, everything we have done in SQL has focused on individual rows. We used to select rows, filter rows, sorted rows, and we used to join some rows. But here's the reality of how SQL is used in the real world. Businesses almost never ask that, show me every row in the table. Instead, they ask, how many employees do we have per department? What is the average salary? Which states generate the highest revenue? Who are most active customers or the most loyal customers? These are summary questions. And the moment SQL moves from showing rows to answering summary questions, you made a huge transition. We enter the world of group by and aggregation. So far, you had a basic introduction to these functions. This chapter is where SQL stops being data relevant and starts becoming data analysis. If joins helped us connect data, group by helps us understand patterns inside the data. Now let's go with the part 1. What group by actually does. Let's build the intuition first. SQL looks at each row independently. But when you use group by, SQL changes how it thinks. Instead of processing row by row, SQL tries to process in a different way. It tries to group rows that share the same value, applies calculations to each group, returns one row per group. So you are no longer working at row level, you're working at a group level. Think of group by as a machine that takes many rows, bundles them into logical buckets, and produces summarized information. This is the foundation of reports, dashboards, KPIs, analytics, and business intelligence. Now let's go to the part 2. First, group by, simple and clear. This could be our first query here. Now let's go through the sample query on my screen. So here we have a department ID and we're trying to count the number of employees per department, and we will be aliasing it as total employees, and we are selecting this data from employees and we are trying to group it by department ID. Now what we want to know is the question. So it is basic and simple. We want to know how many employees are there for each department. Instead of listing employees one by one, we try to group them, and once we group them, we will try to count them and then execute the query. So let's execute this query and see the output. So basically we have 5 departments here. One department is not assigned, so that particular one is based on Frank that we earlier executed. So let's take a pause and understand what SQL is doing here. It is scanning the employees table, grouping rows by department ID, counts the total number of employees inside each group. Every department becomes one row in the result. Now, one important observation that you need to have here is employees with null department form a separate group altogether. This is real world behavior. Missing data doesn't disappear. Now let's make a transition to part 3, where we try to group by with join, making output business friendly. IDs are useful for databases, but people don't think in IDs. They think in names. So let's improve this query by using a join function. So let's quickly go to Workbench and see the code on my screen. So previously we had no names to the department, right? Now to make it more sensible, we are trying to combine employees table with the departments table, because departments table has the name of the department, right? The null 1, 2, 3, 4 doesn't make sense. So it could make a lot sense when we had an actual department name. So for this, let's execute this particular query, and you already know how the left join works and on what basis did this particular employee table establish a join with employees table, right? So here we have department ID from employees table, and here we have department ID from departments table. Based on the match and the type of join that we're using is left join, what it does is it keeps all the entries from the left table, which is the department or employees table, and the matching elements from the right table, which is the departments table, right? So employees is the left and departments is the right. Now we will be grouping by department name. So let's execute this query, and there you go. We have HR, engineering, finance, and the null department, and the total number of employees working in each department. Now we join employees with departments. We grouped by department name. We made the output more readable for leadership. This is how SQL is used in HR reports, management dashboards, workforce planning, and a lot more. Now, one very important learning from this part is joins usually happen before group by. Now let's make a transition to part 4, which is slightly tricky group by, and we will be using multiple columns here. Now let's raise the difficulty slightly. Suppose the business asks you this: how many employees were hired per department per day? This means we group on more than one column. So let's execute the code right on my screen. So if I scroll down, here we have another slightly tricky query. So here we are trying to select the department ID, hire date, and we are counting the number of employees based on the column employee ID, and we are aliasing it as hire count, and we are extracting this data from employees table, and here we are grouping by multiple elements. One is department ID and another is hire date. You might be wondering, will this work? Group by was designed to take multiple entries here, so this totally works. Now let's execute this query and see the output. So we have a department ID and hire date. So based on these dates, we have the total number of recruits that we had on that particular date. Now what's happening here? SQL creates groups using both columns together. Each unique combination becomes one group. This increases the number of results per row. The key rule to emphasize clearly is any column in select that is not aggregated must appear in group by. This rule appears frequently in interviews. Now, let's move to the next part of this module, which is about aggregation functions. So it's a quick deep dive. Now that group by makes sense, let's talk about aggregation functions. These are functions that operate on groups, not individual rows. Now we have a few of them. So let's get started with count function. It is basically used for measuring volume. Let's start with count. You can see a sample query on my screen. So let's go to the workbench once. So here what are we trying to do is we are trying to count the total number of employees from the employees table, right? And we will be aliasing it as the total employees. What this basically does is it counts all the rows. Now with grouping, back to my screen. So let's execute this and we have about total employees. Now about grouping, we have the query right on my screen here. So what we're basically trying to do is we are basically trying to group the total number of employees per each department. So we are adding the department ID and counting the number of employees in there. So let's execute this query. There you go. So count of column ignores all the nulls. Count of star counts total number of rows regardless of how many entries we have. Count answers questions like how many, how frequent, how active. Now with that, we have the next aggregate function, which is a sum function measuring total value. Sum is used for totals. Let's see a code. So here we have select sum of salary as total salary from employees table. Let's execute this and we have about 8,70,000. Now let's make it a little more meaningful. Explain the business context, budget allocation, cost control, department-wise spending, right? These will be the business level questions. If you categorize by departments, then you will have a clear answer on the budget allocated for each department. Next aggregate function is based on average, typically measuring some value such as average salary per department. So let's execute the code. So we also have another query on sum. So let's execute this as well. So once executed, you will have, this is the amount of salary or budget allocated to each department. Now let's go with the average function again as discussed. So here we want to find out the average salary allocated per employee in each department, which is similar to the previous query. So let's execute this and we will have the answer. So the average salary allocated per each department is, for HR we have 60,000, for engineering we have 1,08,750, for finance we have 95,000, and for marketing 80,000. So this is the average salary which we have allocated for each and every department. Now the next aggregate functions are minimum and maximum, and it is finding the extremes. So let's go for an example, and the business use cases are salary bands, compensation gaps, identifying anomalies, and a lot more. So here we have the department name. So minimum salary as lowest salary per department, maximum salary is the highest salary per department, and we're extracting this from employees table. And since we need the department name, we are joining this with departments table D, and based on the column department ID, and we are grouping by department name. So let's quickly execute this query, and there we have the lowest and highest salaries of each department: HR, engineering, finance, and marketing. So the lowest salary in HR is 50, highest is 70, engineering is 90, and 12 or 1,20,000, and 95,000 for finance, and 95 is the highest as well. Marketing, we have 75 as the low and 85 as the highest. Now let's make a transition to the part 6 of this module, aggregations with dates, transaction data. Now let's switch tables and think like analysts, like orders per day. Now let's go through the query here. So this is one query that highlights the number of orders per day. Let's execute this. So we have about so many orders, and a few dates are where we had multiple orders, and we also have few dates where we have about a single order per day. And let's go through the next query that we had, which is revenue per day. So this particular query is based on revenue per day. Let's execute this, and we have 25,12,6 as the highest revenue which we earned, which is December 6th, 2025. So this is how daily KPIs are built. These queries sit behind dashboards. Time-based aggregation is extremely common. Now with that, let's make a transition to part 7 of this module, which is about having clause, filtering groups, and it is really critical. Now we address one of the most misunderstood concepts of SQL, where filters rows, having filters groups. You cannot use aggregation functions inside where. I guess this is the second time I'm repeating this because this is really important, and most of the times we confuse with this. This is why having exists, and basic having examples are the following. departments with more than 2 employees. And for executing this command, let's take a quick look on the screen. So here we have the query. Select department ID, count the total number of employees as department's employee count from employees table, and group by department ID having count of employees greater than 2. So let's execute this. And we have that one particular department where we have about 4 employees. I think it is engineering department. Now let's also discuss the execution order once again so that you have a quick understanding of how the execution order really works in SQL, and it could be helpful for your homework that we had in our previous model. Group by runs first, aggregation happens next, having filters the result, and having with join. And for this, let's go with an example. Right here, we will be combining both having with join. So here we are trying to have this particular business question: which departments are highest paying? So here we have a department name, average salary, and employees, and we are trying to find out the employees with paycheck more than the average paycheck of every employee. So engineering and finance are those two teams which are paying more than the average salary. So we have our final answer. So those two departments which are having the highest salary, right? Tricky, having multiple conditions. So is our next repeat. Now moving next is another tricky question, and this particular one is based on having multiple conditions. So let's go back to the MySQL workbench and have a look at the query. So multiple conditions is right here, having count more than 2, and the average salary should be more than 80,000, right? So let's execute this query. The only difference is we are trying to have the average salary should be more than 80. So engineering team is the one which has employee count as 4, and average salary is 1,08,750. So having can use multiple aggregations. This is advanced interview level question from SQL, so you can make a note of it. Now moving further, we have part 8 of this module, filtering grouped results, where we have where along with having together. This is where learners truly level up. Now let's have a small business requirement. Show average salary per department for employees hired after November 2025, but only include departments where the average salary is above 85,000. So let's take a quick look on the code. So this is the code that we will be executing. So we have put the hire date, which is November 1st, 2025. We're trying to group by department, and the same query condition, which is salary should be more than 85,000. So let's quickly execute this query. So we have 2 departments in that way, engineering and finance, where we recruited employees after November 2025, and the salary is above 85,000. Now let's look at the execution order. From executes first, then join, followed by that we have where, then group by will be executed, followed by that we have having clause, then we will select, and lastly we will order by. This is core analytical SQL thinking. Now let's move to the part 9 of this module, which is a capstone query, and this could be real dashboard logic. Let's end this with a realistic analysis query. Back to the workbench. So here we have the query. So here what we are trying to do is we are trying to group by order date, and we should be having some amount greater than 800, and total revenue should be in descending order. We are trying to find out those particular columns, which is order date, count total sales, sum of total revenue, and average order. So let's execute this query, and we have the output over here. Now let's understand this. Multiple aggregations are done together. Filtering is done using having clause. We have sorted the results, and this query could power a business dashboard. Now let's also discuss some of the common mistakes that learners should be warned about. Now let's discuss some of the common mistakes that learners make and we should be alert about. So the first one is about forgetting group by columns using where instead of having, mixing row level and group level logic, ignoring null behavior, aggregating without the business context. Now, why this chapter was a turning point? At this stage, learners cross an important milestone. If you have understood group by, aggregation functions, having clause, where clause, filtering group data, then you're no longer just querying data, you're analyzing data. This is the skill that powers dashboards, drives decisions, gets tested in interviews, separates beginners from professionals. In the next chapter, we will build on this foundation with advanced analytics concepts, including window functions and ranking. Now we enter the module 7, which is about subqueries and nested queries in SQL. So it could be single row, multi-row, correlated subqueries, plus usage in select, from, and where. Now let's have a quick introduction to Now let's have a quick introduction to why subqueries matter so much. So far in SQL, we've been answering direct questions. Some questions like, show me the roll number of employees, show me departments, show me total revenue per day. But real business questions are rarely simple. Businesses ask questions like, employees who can earn more than the company's average, departments with higher than average salaries, customers who place more orders than most of the other users, sales days that outperform the overall trend. Notice something important. These questions depend on the result of another query. And that's exactly why subqueries exist. A subquery allows one SQL query to depend upon the result of another SQL query. This chapter is where SQL becomes logical and layered, not just procedural. Now, part 1 of this particular module, what exactly is a subquery? So, let's define it. Subquery is a query inside another query. It runs first, produces a result, and that result is used by another outer query. Think of subqueries as asking a question, using the answer to ask a better question. In interviews, this is often described as SQL inside SQL. Simple visual example can be understood in this way. Inner query calculates something, and outer query uses that calculation to provide some better answer. SQL reads subqueries inside out, not top to bottom. This mental shift is really critical. Now, let's go through some examples. So this brings us to part 2, single row subqueries. What is a single row subquery, you ask? A single row subquery returns exactly one value used with operations like equals to, greater than, less than, greater than or equals to, less than or equals to. Let's take an example on my screen. So employees earning more than the average salary. So let's find the average salary first. Let's look at a code on my screen. So here we are trying to find out the average salary of the overall employees table. So the average salary is 87,000. Now instead of hard coding this value, we will nest it, right? So here we want to find out the employee ID, name of the employee, and salary from employees table, where salary is more than the average salary. So here we are ingesting this particular subquery that we recently executed, right? So this happens to be the single line subquery that we are discussing as of now. So this particular single line subquery will be ingested inside the outer query. So this happens to be the inner query, and this happens to be the outer query. Now let's run this. There you go. So we have about 1, 2, 3, 4, 5 employees who earn more than the average salary of other employees. So let's take a pause and understand what's happening here. Inner query calculates company's average salary. Outer query performs and filters employees above the average salary range. Important business interpretation to understand here. Who are our top earners compared to the organization? This is a classic interview question. Now, let's take another example. Employees earning more than the maximum salary in a specific department. Let's say HR. Now, let's take an example on my screen. So here, we have a subquery which is select maximum salary from employees where department ID is equals to 1. So the department ID 1 is none other than the HR department. So we are encapsulating this particular inner subquery onto the outer subquery, which is trying to select the name, salary from the employees table, right? And where salary is greater than a number which is the result of this particular subquery, which is the maximum salary of employees. Now, let's execute this query. Control Enter, and there you go. Now, let's take a pause and understand how is this working. The inner query returns the maximum value of salary from HR department, and the outer query compares every employee against it. This shows targeted comparison logic. Now, let's make a transition to part 3, where we will have multi-row subqueries. So what is a multi-row subquery? A multi-row subquery returns more than one row. It is most commonly used with operators like in, any, all. So for this, to understand in a better way, let's take an example. And the example question is employees in departments with average salary greater than 90,000. So first, let's identify all the departments. For that, let's take a look on my screen. So let me quickly write a small query. Star from departments. So we have 1, 2, 3, 4 departments: engineering, HR, finance, and marketing. Now we need to execute this particular subquery where we are trying to find out department ID and employees and department having salary more than 90,000. Now let's execute this. So we have department IDs 2 and 3 where they have greater higher salary or the average salary. Now we need to use this particular query inside another external query. So this is the outer query, this particular section, and this was the subquery that we just executed. Now we need to encapsulate this particular subquery inside the outer query, and now let's execute this. So we have the name of the employee, their salary, and their department ID. So as discussed in the first subquery, these are the employee or department IDs and their relevant employees. Now let's understand this clearly. Inner query returns multiple department IDs and outer query filters employees belonging to those departments. Now the business question answered here is which employees work in higher paying departments. So that's what the answer we gave. Now let's take another example. So the example 2 is we want to find out customers who placed more orders than the average. Now let's execute this particular query. So there you go. These are the customer and their IDs 1 and 2 and their placed orders 3 and 4. These are the most loyal customers. Now let's understand the working of this particular code segment. Customers who placed more orders than average. Now let's understand this carefully. Inner subquery calculates order counts per customer. Next level calculates average order count. Outer query filters high activity customers. This is advanced analytical SQL, not beginner stuff. Now let's make a transition to part 4, which is about correlated subqueries and most important concept. Now, what is a correlated subquery? A correlated subquery depends on the outer query and it executes once per row and cannot run independently. Think of it as for each row, run a subquery that depends on that particular row. This is where SQL starts to feel like programming. For that, let's take an example. So this is the particular example we are going to execute. The question here was employees earning more than their department's average. Now let's understand this particular example. Outer query processes each employee. Inner query recalculates average salary for that particular employee's department. Now the comparison happens row by row. Now the business interpretation. Who are the top performers inside each department? This is one of the most frequently asked SQL interview questions. Now, let's consider another example. Orders that occurred after customer's first order. For that, let's take a quick look on the code on my screen. So here it is. We are using two different queries, the outer query and the inner query. So the inner query is where we selected minimum orders and customer ID is equals to customer ID from orders table. And we are joining or we are applying self join here, basically combining the orders table with itself. Now let's execute this query. There you go. Now let's understand this. For each order, we find the customer's first order. We keep only the later orders. This helps to analyze repeated behavior. Now what is used here? We use this in retention analysis, funnel tracking, behavioral analytics. Now with that, let's make a transition to part 5. Part 5 is about subqueries in where clause. So it is a basic recap plus best use. This is the most common place where subqueries are used. Let's take an example. So here the business query is sales on high revenue days. Let's understand this. Inner query identifies high revenue days. Outer query fetches detailed sale rows. This pattern is used constantly in analytics. Now let's execute this query. So there you go. We have the answer. So we have two different entries, sale ID 8 and 9, and the amount was 400, 50, and 600. Now let's make a transition to part 6 of this module. So part 6 is about subqueries in SQL clause and will have calculated columns. Subqueries can act like dynamic columns. So let's take an example. So this is our example here. Let's execute this. So we have the output. We have a name of the employee, salary, company's average salary, and difference from average. Now let's understand what did we execute here. Salary compared to company's average. The inner query runs once, adds context to every row, makes reports more meaningful. Now it's great for dashboards and exports. So here what we did is we find out the salary of the employee and company's average and what's the difference, right? The difference amount that they are earning more than the average salary. Now this drives us to part number 7 of this module, which is about subqueries in from clause, or also known as the derived tables. Subqueries from act like temporary tables. For example, department-wise salary summary. Let's take a look at the example on my screen. So this is the code that we will be executing, and here we have the output. Now let's understand what is the logic that we implemented here. The inner query creates a derived table, outer query filters it, and this improves readability for complex logic. This is a stepping stone to CTEs and window functions. Now let's move to part 8. So part 8 is about when to use subqueries versus joins. Now one important discussion. Now with that, we make a transition to module 8, which is about the difference, right? When to use subqueries and when to use joins. Use subqueries when logic is layered. Aggregation is needed first. Readability improves. And when to use joins? Joins are used when data relationships are direct, performance matters most, data volume is really large, and professionals choose clarity and performance. Now let's also go through some of the common mistakes to warn learners about. So using equals to instead of in, expecting multi-row subqueries to return one value, forgetting correlation logic, overusing subqueries where joins are better, and the last one, ignoring performance implications. Now why this chapter was a milestone? If joins taught SQL how tables relate, subqueries teach SQL how logics relate. Once you understand single row subqueries, multi-row subqueries, correlated subqueries, subqueries in SQL, from and where clauses, you can answer almost any analytical question in SQL. This chapter is a bridge from intermediate SQL to advanced SQL to interviews to real production analytics. In the next chapter, we will take this logic and supercharge it using window functions and ranking, which solve many problems more efficiently. Now we transition into module 8, which is about data modeling and relationships. So primary keys, foreign keys, relationships, ER diagrams, and normalization are the topics discussed in this particular module. Now let's have a quick introduction. Why this module defines your SQL maturity. Before we begin this chapter, I want you to pause for a moment. Up to this point in the course, you've been learning how to talk to a database, how to select data, how to filter it, how to join tables, how to aggregate results. That's important. Okay, this chapter answers a deeper question. Why does a database look the way it does in the first place? This chapter is not about writing queries. This chapter is about thinking like a database designer. And here's a reality check that most tutorials won't tell you. In real world, SQL queries are easy to learn. Poor data modeling destroys companies. Most production bugs are data design bugs. Most analytical errors come from bad relationships. If data modeling is weak, joins become confusing. Data becomes inconsistent. Reports contradict each other, performance drops, and most importantly, trust in data disappears. This is why senior designers, architects, and analytical leaders care deeply about data modeling. This chapter will help you understand how professional systems are designed, read any database schema with confidence, answer system design interview questions, avoid beginner-level modeling mistakes, build databases that scale logically, not just technically. Think of this chapter as the architecture class of SQL. Now, let's start with part 1. What is data modeling? Now, thinking before coding is nothing but data modeling. Let's start with the foundation. So, what do you mean by data modeling? Data modeling is the process of identifying entities, defining their attributes, establishing relationships, enforcing rules and constraints. In plain language, data modeling is deciding how information is structured, stored, and connected before data even exists. A good data model answers what are core subjects of the system, what information belongs to each object, how do objects relate to each other, what rules should never be broken. Now let's go through a real-world analogy to understand this better. Imagine you're designing a hospital data system. You don't start by randomly creating tables. First, you think. You think about patient's data table, doctor's data table, appointments table, departments table, prescriptions table, bills table. Then you start asking questions. Can a patient have multiple doctors? Can a doctor treat multiple patients? Does an appointment exist without a patient? This type of thinking is nothing but data modeling. SQL syntax comes later in the picture. Why data modeling comes first is because of some reasons. First, many beginners jump directly into creating tables. Start inserting data, worry about queries later. Now, let's discuss this in terms of professionals. Professionals design the data model first, validate relationships next, anticipate growth in the future, and prevent any type of inconsistency. Data modeling is about future-proofing your dataset. Now, this makes our transition to the part 2 of this module, primary keys, the primary identity of any data. Let's talk about the most fundamental concept in relational databases. What is a primary key, you ask? A primary key is a combination or a column of columns that uniquely identifies each row in a table. Every record must have one identity, one unambiguous reference. In simple terms, a primary key answers one question. How do I uniquely point to this exact row? Now, why primary keys exist? This is one particular and critical insight. Imagine a table without a primary key. You have two customers with the same name, same city, and same phone number as well. Now you ask yourself, which row do I update? Which one do I delete? Which one does a specific order belong to? Now your answer. Without a primary key, data becomes unreliable. That's the answer. That's why we do have a primary key. It's like an identity for your data entry. Let's understand through a real world analogy. For example, government identity. Your name can change, your address can change, your phone number can change. But the passport number, the Aadhaar number, social security number, which will not change. This uniquely identifies you. That's exactly what a primary key does for a row. Now, let's discuss the characteristics of a strong primary key. A good primary key should be unique, no duplicates ever, it should not be null, its identity cannot be missing. Third one is it should be stable, should not change over time. And next one is it should be minimal, prefer single column keys. Now, let's understand one difference between natural keys and surrogate keys is very important. Natural key comes from business data. Example, email, username, PAN number, etc. Now, what are the problems here? So the problems are this can change, this can be duplicated, it can be tied to business rules. Now, let's understand the surrogate key. Surrogate keys are artificially generated ones. For example, auto increment ID. What are the benefits of using surrogate? They are simple, stable, and efficient for joins. Most modern systems use surrogate keys to enforce uniqueness separately. Now, a quick interview tip. Should email be a primary key? A most mature answer is email can be unique, but emails can change. Better as a unique constraint, not as a primary key. Now, we make transition to the part 3 of this module. Foreign keys, which are connecting the data world. Now comes the concept that makes SQL relational. So what is a foreign key? Foreign key is a column in one table that references the primary key of another table. In simple terms, a foreign key relates a relationship between tables. Why foreign keys exist? Now the next question is, why foreign keys exist? Instead of duplicating data, department name, customer details, product information, we store it once, reference it everywhere. This ensures consistency, reduced storage, cleaner updates. Now let's understand through a real world analogy. Booking a flight. A ticket references to passenger ID, flight ID. The ticket does not store passenger name repeatedly, aircraft details repeatedly. Foreign keys keep systems normalized and scalable. Now, let's go through referential integrity, a non-negotiable rule. Foreign keys enforce you cannot reference a record that doesn't exist. You cannot delete a parent if children depend on it. This protects the database from orphan records, broken relationships, logical corruption. The next one is on delete and on update. These are business decisions. When a parent row changes, should child rows get deleted? Should they get updated? Should the action be blocked? Now to understand this, consider these examples. Deleting a customer with orders, usually it is restricted. Deleting a draft record, cascade is allowed. These are domain decisions, not just SQL syntax. Now let's make a transition to part 4 of this module, relationship types, how data connects. Understanding relationships is the heart of modeling. We have a wide variety of relationship types. Let's start with one-to-one relationship. One record in table A maps to another record in table B. For example, user data table to profile data table, employee data table to ID card data table, person data table to passport data table. Now the next question is, when should you use one-to-one relationship? It is rarely but intentionally used when sensitive data needs separation, optional data exists, performance optimization is required. Now let's consider an example. Authentication data separated from user profile. Now the next type of relationship is one to many or one to n. This kind of relationship is most common. One record in table A maps to many records in table B. Examples: customer table to orders table, department table to employees table, user table to post table. This is the default relationship in relational databases. What's the implementation rule? The foreign key always sits on the many side. This rule alone clears 70% of beginner confusion. The next one is many-to-many relationship, or M is to N relationship. Many records in table A relate to many records in table B. Some of the examples are students table to courses table, products table to orders table, movies table to actors table. Now, junction table concept. Relational databases resolve M to N using a third-party table, two foreign keys, optional extra attributes. This table often stores timestamps, quantities, status, grades, etc. With that, we make a transition to part 5, which is about ER diagrams. It is basically about thinking visually. An ER diagram is a visual blueprint of a database. It shows tables, columns, primary keys, foreign keys, and relationships. Now, why ER diagrams matter in the real world? Before code, architects use or draw ER diagrams. Teams review them. Business rules are validated. ER diagrams prevent rework, confusion, costly redesigns. How interviewers use ER diagrams could be a question. So they want to see logical thinking, relationship clarity, normalization awareness. You don't need fancy symbols. Clarity matters more. With that, we make a transition to part 6 of this module. Normalization, which is about keeping the data clean. Now with that, we make a transition to part 6 of this module, which is about normalization and keeping the data clean. Now, let's talk about one of the most misunderstood topics. What is normalization? Normalization is organizing data to minimize redundancy and dependency. In simple words, avoid duplicate data, avoid inconsistent updates, protect data integrity. Now, why normalization exists? Without normalization, same data stored in multiple places, updates miss same rows, reports contradict each other, and the data trust collapses. Now we have a few different types of normalizations. So the first one is 1F, or the first normal. It is about atomic values and no repeating groups. Now a bad format will be phone 1, phone 2, and phone 3, and a good separate phone table is the best example for this. Now we have this second normal form, which is 2NF, and the rules are: in 1NF, no partial dependency, and it applies mainly to composite primary keys. Now we have the third normal form, which is also known as the 3NF, and the rules are: in 2NF, no transitive dependency, meaning non-key attributes depend only on the primary key. Now let's understand the difference between normalization versus denormalization, which is a real-world trade-off. OLTP systems, highly normalized, write consistency matters. Analytics systems, often denormalized, read performance matters, and professionals choose intentionally, not blindly. And with that, we make a transition to part 7 of this module, which is about real-world case study on e-commerce modeling. Let's design a simple e-commerce system verbally. So we have the following entities. We will be having users, products, orders, order items, and payments. Now let's discuss the relationships. Users are connected to orders in 1 to n, and orders are connected to order items, which is also 1 to n. And the last one is product to order items, which is also 1 to n. No direct order to product, which is m to n, resolved via order items. This is real world modeling in action. Now let's make a transition to part 8, which is about common beginner mistakes. Let's quickly cover some mistakes professionals avoid. So some of the mistakes are using names as primary keys, storing repeated values, missing foreign keys, over-normalizing early, ignoring future growth. Avoid these mistakes and you already think like a pro. Now we enter the part 9 of this module, which is about interview mindset and how to answer design questions. Interviewers want thought process, trade-off awareness, business understanding. Always explain why you choose a structure, why you rejected alternatives, how it scales. Now, a simple summary. Why this chapter changes everything. This chapter transforms how you see databases. You no longer memorize syntax, fear joins, or guess relationships. You now understand structure, design confidently, think long term. This is the difference between a SQL user and a data professional. So now we have entered module 9, which is about indexing and performance tuning. This module will help us understand why indexes matter, creating and using indexes, and query optimization tips. Now, let's have a quick introduction. Why performance is a career skill. Before we talk about indexes, let me tell you something very important. Most SQL learners stop at select, where, join, group by commands. But professionals are judged on performance. In real companies, no one praises a query that works. They praise a query that works fast. They praise a query that works at a scale. And here's the truth. Performance problems don't show up in small datasets. They show up in production. This chapter is all about why some queries are fast, why others slow down as data grows, and how databases search data internally, how indexes change the game completely. If you understand this module, you'll write scalable queries, you'll pass performance-based interviews, you'll avoid production outages, you'll sound like someone with real experience. This is not about memorization. This is about how databases link. Now, the part 1 of this module. Why indexes matter, how databases find data. So, let's start with a simple question. How does a database find data? Imagine a table with 10 rows. It could be fast. And if you have 10,000 rows, maybe your query is manageable. 10 million rows, already you might be thinking your query could be slower. And in case if you had a billion rows, it's a complete disaster. So without indexes, this could become a reality. Now, without an index, the database performs a full table scan, meaning it checks every row one by one until it finds what you asked for. That's like searching for a name in a phone book without an index, reading every page from start to the end. Now, a real-world analogy. Book index versus page-by-page reading. Think of a textbook. If you want to find out a normalization topic, you don't have to read every page. You go through the index, find the page number, jump directly, and that's exactly what a database index does. Now, what is an index? An index is a separate data structure that stores column values in sorted order without pointers to the actual rows. In simple terms, an index is a shortcut for finding data quickly. Why indexes improve performance is your question, right? Indexes reduce disk input-output operations, CPU usage, query execution time. It is especially for where conditions, join conditions, order by conditions, or clauses and group by clauses. Now, important reality check indexes. They speed up reads, slow down writes. Every insert, update, delete commands must also update indexes. So indexes are not free. This is why indexing is a design decision, not a default action. Now, with that, we make a transition to the part 2 of this module, which is about how indexes work internally. Now, you don't need to be a database engineer, but you must understand the intuition. Most databases use B tree or B plus tree structures. Conceptually, data is stored in sorted blocks. Each block points to a child block. Searches are logarithmic, not linear. This means searching 1 million rows is almost equal to a few steps. Searching 1 billion rows is also still manageable. Without indexes, search time grows linearly, performance collapses at a scale. Now, let's understand the difference between clustered and non-clustered index. First, clustered index. It defines physical order of data. Table can have only one, and it is often a primary key. Now, non-clustered index. It separates structure. Multiple clustered indexes are allowed. Points back to table rows. You don't need to memorize this just now. You just understand. Some indexes control how data is stored. Others act as lookup maps. And with that, we make a transition to part 3 of this module, which is about creating and using indexes. Now, let's talk about practical usage. Basic index creation. Indexes are created on columns that are frequently searched, frequently joined, frequently filtered. Now, some of the examples are like user ID, order ID, email address, and other foreign keys. When should you create an index could be your next question. You should create indexes when table size is large, queries use where on that column, and joins happen frequently, and sorting is very common. And the next topic is about selectivity, which is a key performance concept. High selectivity column has many unique values. For example, email, user ID, and low selectivity are few unique values. For example, gender, status, active or inactive. Now, indexes work best on high selectivity columns. Composite indexes sometimes queries filter on multiple columns as well. For example, where department ID is equals to 2 and salary is greater than 90,000. A composite index on department ID and salary can significantly improve performance, but order matters. Department ID comma salary is not equals to salary comma department ID. Indexes follow left to right rules. Indexes and joins, very important part. Indexes on primary keys, foreign keys make join operations faster, more predictable. This is why foreign keys are often indexed. Now, we make a transition to part 4. Query optimization is not magic. It's about reducing work, reducing data scanned, helping the optimizer. Now, the rule 1. Avoid select star. Select star fetches unnecessary columns, increases input-output operations, slows network transfer. Always select only required columns. Rule number 2. Filter early. Use where conditions as early as possible. Filtering early reduces rows, improves joins, and improves aggregations. Now comes rule number 3. Index where and join columns. If a column appears often in where, join, order by, it's a candidate for indexing. Rule 4. Avoid functions on indexed columns. Now let's go through an example which is bad, where year of order date function is equals to 2025. Now let's also go through a good example, where order date is between 2025 1st of January and 2025 December 31st. Functions can prevent index usage. Now the rule number 5. Use explain. Most databases provide explain and explain analyze. These show query plan, index usage, and scan type. Professionals always check execution plan before optimizing blindly. Now comes the part 5 of this module, which is about common performance anti-patterns. Let's talk about mistakes that kill performance. First anti-pattern, over-indexing. Too many indexes, slow inserts, slow updates, and increases storage. Indexes should be intentional, justified, and reviewed. Second anti-pattern is indexing everything. Not every column needs an index. Indexing low selectivity columns rarely helps and often hurts. Now, third anti-pattern, ignoring data growth. A query that works today may fail at a scale or may time out later. Always ask, what happens when this table has 1,000,000 rows or 100,000,000 rows, right? Now, the fourth anti-pattern is blind optimization. Never optimize without measuring, without understanding the plan. Premature optimization is often dangerous. Now comes the part 6 of this module, which is about real world scenarios. Now the first scenario, slow dashboard query. Millions of orders filtered by date range, grouped by customer. Now the solution for this problem, index on order date, composite index if needed, and avoid select star. Now the second scenario, slow join query. Orders joined with customers, foreign key is not. Now the quick fix for this problem is index foreign key, reduce join columns, and check execution plan. Now comes the scenario number 3, which is about reporting versus transaction systems. OLTP, normalized index for writes plus reads. Analytics, denormalized index for reads, sometimes materialized views. Now comes the part 7, which is about interview perspective, how to talk about performance. Interviewers don't expect perfect tuning, deep engine internals. They expect awareness, trade-off thinking, real-world mindset. Good answers mention indexes, execution plans, data volume, and query patterns. Now, some of the bad answers that you should avoid are add indexes everywhere, use faster hardware. A little summary of this module. Why this module makes you professional. Anyone can write SQL that works, but a very few can write SQL that scales, performs, survives growth. This module moves you from beginner level SQL thinking to production ready SQL thinking. From here on, you won't fear slow queries. You will reason about performance, you will design smarter schemas, and you will earn trust in real teams. And with that, we make a transition to the next module. Now we enter module number 10, which is about views, functions, and stored procedures. Up until now, we've been writing queries directly on tables using select, join, and group by, subqueries, and even some window functions. That's great for learning SQL fundamentals. But in real-world organizations, analysts and applications do not write raw queries every time. Instead, SQL logic is abstracted, reused, and secured using database objects. This is where views, functions, and stored procedures come into the picture. Think of it like software development. Views are reusable layers, functions are calculation utilities, stored procedures are like back-end APIs running inside the database. Mastering these concepts separates someone who knows SQL from someone who works with SQL in production systems. Now, SQL views. What is a view? A SQL view is a virtual table created with a select query. It doesn't store any data by itself, but it stores the logic. Whenever you query a view, SQL runs the underlying select query. It fetches fresh data from the base tables. So remember, tables store data and views store business logic. Why views exist in real systems is the question you ask. There are four main reasons companies use views. First one, simplification. Analysts don't want to write complex joins every time. So the next reason is consistency. Everyone should calculate metrics in same way. The third reason, security. Views hide sensitive columns from certain users. The fourth and most important reason is maintainability. Change logic in one place and it updates everyone. And those were the four reasons why views really matter in real world data analytics. Now, let's go through some examples. View example number 1, right on my screen, which is about employee details view. Right? We are creating a view on the employee details. Now, let's imagine you are an HR and you want employee details along with department names without writing joins repeatedly. Now, for that, let's create a view. So here, we are creating a view using the word or the keyword create and the keyword view. And this is the customized name that you are providing to your view, VW employee details. And inside this view, you will have this particular query where you are selecting employee ID, employee name, employee salary, hire date, and you're also using department, right? So here you can see the D letter. So this means you are using a different data table, which is department's data table, and from employees, and you're joining that particular department's table based on the foreign key department ID and the keyword, the primary key in department table, which is department ID. Right? This is the query, and this is totally a join, and this is your view. Now, let's execute this so that your view is successfully created. So I have executed this query previously. So here you can see VW employees details already exist, right? If you want to extract the details from this particular view, all you need to do is select star from view, which is this one, and you'll have view here, right? Let's have a quick understanding. So when you execute this particular query, you create a reusable virtual table. You'll have a left join here, which ensures that employees without departments are still visible. For example, contractors or new hires, the Frank, which we have in our table, he doesn't have a department here, right? In our previous section, we have discussed about that intentional missing of department for Frank. And this view hides the complexity of joins. Now, so we have already used the view to extract the details, right? Now the key point, SQL executes the join behind the scenes. The user sees clean results. This is exactly how dashboards and BI tools work. Let's go through another example in view, which is department salary summaries. And what's the business question here? The business question is, what is the average and total salary per department? Now, let's go through the query. So here we have the second view, which says department salary summary. And we are creating this particular view using create and view keywords. And here we have department name, counting the total number of employees in each department. And we are aliasing this as employee count, and average aggregate function. And we are aliasing it as average salary. Some aggregate function as the total salary alias from department's team. Left join the employees on department ID from department's table with a department ID from employees table and group by department name. We already created this view. Let's say if we try to execute this, we'll get an error which says view department salary summary already exists. Now, how do we use it? So you can just use the same select function. You can copy and paste it here and replace this particular view employee details with this particular view name, salary department, and enter to use this view. And there you go. So we have the department name, employee count, average salary, and the total salary, right? Now we enter a state where we should understand why views matter. So views matter when you're creating monthly reports, leadership dashboards, financial analysis. Without views, you would write the same query multiple times, risking inconsistent results and creating a maintenance headache. Now, a quick interview insight. Now, if someone asks you to explain what is a view, then you should not answer use store data. As we discussed in the beginning section, views never store any data, but they store only the logic. So the correct question would be, views store query logic. They abstract the complexity and keep the data dynamic. Now we transition to the next part, which is the SQL functions. Now let's understand what exactly is a function. A SQL function is a reusable block of logic that accepts input, returns a single value. It can be reused inside a select, where, order by condition, and you can think of it like an Excel formula that works directly on your data table. Why functions matter? Functions avoid repeating case statements in multiple queries, centralize business rules, improve readability, reduce errors. Now, let's also go through some examples. Now, the first example is salary category. Now, what is the business need here? The business need is we can classify employees as high, medium, or low salaries, right? Now, let's go through the query. So here we have the delimiter, and we are creating a function which is function salary category, which returns worker type of data 20 and deterministic begin here. So declare category, and the categories are high for employees having greater than 1 lakh salary, medium for employees having greater than or equal to 70,000 salary, and the other category is set to low. Now this function is already created. Now how to use the function? Now we are using the function here, select name, salary, and the function name as salary band from employees. Now let's quickly hit enter, and we have all the details right here. Now we have the second example for function, which is experience calculation. Now before that, let's see how the output works. So basically this particular query returns worker type of output, and deterministic, which is same output, always returns the same output and helps the optimizer if or else if function and encodes the business rules using the function. Now this approach keeps your queries clean, readable, and maintainable. Now as we discussed, the second function, which is experience calculation. What this does is it basically calculates how many years of experience does each employee have. Now where is this being used? So for that, let's go to the workbench. So we have already created this particular function, which is function experience in years. Now we have deterministic, returns int type of data type, and we will use this particular function here and execute the query. So Alice, I think this particular industry was created recently, so none of the employees have crossed 1 year of experience. So that's great, not a big deal. Now we enter the next part, which is about stored procedures. And before that, let's understand the difference between function and a view. When comparing views and functions, there are few points to note. First, their purpose. A view is designed to be reusable query. It encapsulates the logic of one or more tables so that anyone can access it without writing or rewriting joins and aggregation. A function, on the other hand, is reusable calculation. It is meant to perform specific logic or transformations on data. Second, what they return. A view returns a result set, essentially behaving like a virtual table that you can query just like a regular table. A function, on the other hand, returns a single value which can be used directly in calculations or conditions. Finally, where they are used. Views are referenced in the from clause of a query, just like any other table. Functions, on the other hand, are used in select statements, where conditions, or even order by clauses whenever a value needs to be computed. In short, think of views as query containers and functions as calculation helpers that make your SQL cleaner and more reusable. Now, a quick interview insight. A good explanation is functions encapsulate calculations while views encapsulate data relationships. Now we enter into the stored procedures. Now what is a stored procedure? A stored procedure is a named set of SQL statements stored in the database. It can accept parameters, execute multiple queries, return result sets, enforce business workflows. Think of it as a backend logic running inside the database. Now, why stored procedures exist? They reduce application database traffic, improve performance, improve security, standardize business logic, and a lot more. Now, let's go through an example. Now, the example is about employees by department. And what's the business requirement? They return all employees for a given department. For that, let's go through a sample query on my screen. So here's a procedure that we recently created, and the procedure name is SP get employees by department. Now, it's already created and we cannot create this procedure once again. So let's simply call it. So there you go. So all the employees from engineering department are being called here. Now, why it matters? Applications call the procedure. Users never see the underlying tables. Logic is centralized. And now let's go through the next example on procedures, which is department salary summary. Now let's go through the procedure name, which is department salary summary. And since this is already created, we can just call it and execute it. So this is what we have. So we have engineering, HR, finance, marketing, and their employee count, average salary, and the total salary. Proceeding ahead, we have another example in procedures, which is in and out parameters. So here we have in and out parameters. So we are providing customer ID, and out will be the order count. Now this particular procedure is created. Now we can call this particular procedure and then select the total orders, and here we have the output, which is a total of 4 orders. Now what was the business use case? They return total orders from a dedicated customer. Now calling it will give you the results. Now let's have a quick understanding between the stored procedures versus the function. When we compare functions and stored procedures, there are 3 differences to keep in mind. First, what they return. A function always returns a single value, making it perfect for calculations or deriving a specific result. A stored procedure, on the other hand, can return full result sets and even use out parameters, which makes it ideal for handling workflows or multiple operations at once. Second one, how they are being used. Functions can be called directly inside a select statement, so you can embed them in queries whenever you need a calculated value. Stored procedures, on the other hand, cannot be used inside a select. They are executed independently. Finally, their primary use case differs. Functions are primarily used for calculations like categorizing salaries or computing experience. Stored procedures, on the other hand, are better suited for workflows like fetching all employees for a department, updating multiple tables, or encapsulating business logic. In short, think of functions as a calculation tool and stored procedures as a workflow engine inside the database. Now, a final summary. Views improve readability and consistency. Functions improve reusability of logic. Stored procedures improve performance and control. Mastering these concepts prepare you for data analyst job roles, business analyst interviews working with production level databases, and backend and business intelligence systems. Now this finishes the module 10, and with that we transition to the next module. Now we have entered module 11, which is about transactions and error handling in SQL. Before we talk about SQL transactions, error handling, or even asset properties, let's take a moment to understand why this chapter matters so much. Until now, we've been writing SQL queries that read data, filter rows, and analyze information. But in real systems, SQL is not just about reading data. SQL is also responsible for changing data, and once data changes, the consequences become serious. In production systems, a single SQL mistake can lead to incorrect salaries being paid, orders being duplicated, money being deducted twice, customer records becoming inconsistent, or the worst case, complete data corruption. This is where transactions come into play. Think of transactions as the safety net of SQL. They ensure that when multiple changes happen together, they either all succeed or nothing happens at all. This chapter will help you understand what SQL transactions really are and how databases protect data integrity, why asset properties are critical in enterprise systems, and how databases deal with errors gracefully. This is one of those chapters that separates beginners from professionals. Interviewers love this topic. Architects expect you to understand it, and production systems depend on it every single day. What is a transaction is our first question in this chapter. At a very simple level, a transaction in SQL represents a group of database operations that are treated as one single logical unit of work. Instead of executing each SQL statement independently and immediately making its changes permanent, the database deliberately groups multiple statements together and evaluates them as a whole. In practical terms, a database makes a promise. That promise is simple but powerful. It says either every change inside this group must succeed together or none of the changes should be applied at all. There is no middle ground and no partial success. To understand why this concept exists, let's step outside the world of databases for a moment and think about real world scenarios that almost everyone can relate to. Imagine you're transferring money from one bank account to another. This process always involves at least two steps. First one, money is deducted from account A. Second, the same amount of money is added to account B. These two steps are logically connected. One step cannot exist without the other. Now pause and ask an uncomfortable but important question. What happens if the system crashes after the money is deducted from account A but before it is added to account B? From a user's perspective, that situation is completely unacceptable. Money has vanished without reaching its destination. Trust in the system is broken. Databases face the exact same challenges. In SQL, real-world operations rarely involve a single statement. A business process might require updating one table, inserting records into another table, and deleting rows from a third table. Each of these statements may succeed individually, but from a business perspective, they are not independent. They are a part of a single operation. If one of these steps fail, allowing the others to remain would leave the database in an inconsistent and unreliable state. That is why these actions must behave like one combined operation, not three separate ones. This logical grouping of multiple SQL statements into one indivisible unit is what we call a transaction. Now, why transactions are needed is your next question. Without transactions, databases would behave like a collection of isolated commands that execute independently without awareness of each other. While this might sound simple, it quickly becomes dangerous in real systems. Imagine a database that executes every SQL statement immediately and permanently without any ability to reverse or group changes. In such system, failures would create chaos. Partial updates would become common. Data mismatches would appear across tables. Relationships defined through foreign keys would break silently. Reports and analytics would start showing numbers that do not align with reality. Let's take a very common example from an e-commerce system. An order is created in the orders table. Payment processing begins. The payment fails due to a network issue or insufficient balance. However, the inventory system has already reduced the stock count for that product. Now the database shows an order that was never paid for or inventory that no longer exists. This is not a rare edge case. It is exactly the kind of scenario that happens in real systems every day if the transactions are not used correctly. Without transactions, SQL would simply execute each statement in sequence and move on, completely unaware that something went wrong midway. The database would not automatically understand that these operations were connected logically. Transactions introduce control and intent into this process. They allow us to clearly tell the database when to start tracking changes, when to confirm and permanently save those changes, and when to cancel everything and revert back to the original state as if nothing ever happened. This level of control is not optional in modern systems. It is essential. Banking platforms rely on transactions to protect financial accuracy. E-commerce systems use them to ensure orders, payments, and inventory always remain in sync. ERP systems depend on transactions to maintain consistency across complex business workflows. Payroll systems cannot afford partial salary updates. Analytics pipelines and data warehouses rely on transactions to ensure reporting data is trustworthy and complete. In short, transactions exist because real systems fail, networks break, users make mistakes, and databases must be prepared for all of it without compromising data integrity. Now, we land into the next part, which is begin, commit, and rollback. It is the core of SQL transactions. Now that we understand what a transaction is and why transactions are necessary, it is time to focus on the three most important commands that make transactions actually work in SQL. These commands form the backbone of transaction control in every major database system used in the industry today. Those three commands are begin, commit, and rollback. You will encounter them in MySQL, PostgreSQL, SQL Server, Oracle, and almost every enterprise-grade relational database. While syntax variations may exist, the underlying concepts are universal. If you understand these three commands deeply, you understand how databases protect data from mistakes, failures, and unexpected crashes. Let's take them one by one and truly understand what each command does, not just at a syntax level, but at a conceptual level. Now, let's start with begin, or also known as a start transaction. The begin statement marks the starting point of any transaction. Conceptually, begin tells the database something very specific and very important. It tells the database, from this moment onward, do not permanently save any changes yet. Before begin is executed, every SQL statement typically operates in what is known as auto commit mode. That means each individual statement is immediately finalized and written permanently to the database. Once executed, there is no easy way to undo it. Begin changes this behavior. When you execute begin, the database switches into a controlled state. From this point forward, every insert, update, or delete statement is tracked internally by the database engine. The changes are applied in memory or in temporary structures, but they are not yet committed to the permanent storage. This distinction is extremely important. At this stage, the database remembers what has changed. The original data is preserved internally. Other users do not see the changes. The system is effectively waiting for your final decision. A very helpful way to think about begin is, imagine opening a draft document. You start editing the document, but nothing is published yet. You can add text, remove sections, or rewrite entire paragraphs. But until you click save or publish, the changes are private. Begin creates the same draft-like environment for database operations. This is why begin is often described as the moment when the database starts recording intent rather than finalizing the action. Now, visibility of changes after begin. One subtle but critical aspect of begin is visibility. Once a transaction has started, the changes made inside that transaction are usually not visible to other users or sessions. This means you may update a salary inside transaction. Imagine multiple analysts running reports while data is half updated. Without isolation, reports would show unpredictable results. Begin creates a protected workspace where changes can be reviewed, validated, and finalized safely. Now let's dive into commit. Once you have executed all the necessary SQL statements inside a transaction and you are confident that everything is correct, you use the commit command. Commit tells the database that everything that has happened since begin is correct. Make it permanent. This is the point of no return. When commit is executed, the database takes all the track changes and writes them permanently into the disk. At this moment, the transaction ends. The database is updated. Other users can now see the changes. The old data is replaced by the new data. From a conceptual perspective, commit is equivalent to clicking save or publish. Until this moment, everything was reversible. After this moment, the changes become a part of the official database history. It is very important to understand that there is no undo after you use commit. Once the database confirms the commit, the transaction is complete. If a mistake is discovered later, it must be corrected with a new SQL statement, not by reversing the commit itself. This is why commit should only be executed when all statements have run successfully, all constraints are satisfied, the data makes logical sense, The business rule has been fully applied. Professional developers and database administrators treat commit with respect because it represents finality. Now we have durability and commit. Another important idea connected to commit is durability. When a database confirms a commit, it ensures that the changes are safely returned to persistent storage. Even if the server crashes immediately after, the committed data will still exist when the database restarts. This guarantee is one of the reasons relational databases are trusted for critical systems. Commit is not just a logical confirmation. It is a promise that the data will survive failures. Now we have rollback. While commit represents success, rollback represents recovery. Rollback tells the database something went wrong. Cancel everything that happened since begin. This could be due to a constraint violation, a failed business rule, an unexpected error, a manual decision by the user, or even a system failure handled gracefully. When rollback is executed, the database discards all track changes from the current transaction. Every insert, update, or delete is undone, and the database returns to its exact previous stable state. It is as if the transaction never happened. This behavior is what makes transactions so powerful. Instead of leaving behind partial updates or corrupted data, the database cleans up everything and restores order automatically. This is why rollback is often called the panic button of SQL transactions. When something feels wrong, rollback ensures safety. Now we deal with rollback and data integrity. Rollback protects data integrity in situations where partial success would be dangerous. Consider again the banking example. Money deducted from one account, errors occur before adding money to another account. Rollback ensures that the deduction never truly happened. The system goes back to a consistent state where balances still make sense. Without rollback, errors would permanently damage data trust. Mental model for transactions. A very effective way to remember how these commands work together is to use a simple mental model. Think of it like this. Begin means start recording changes. Commit means accept and save changes. Rollback means forget all changes. And this mental model is powerful because it works across databases, tools, and even interview discussions. Whether you're working with MySQL, PostgreSQL, SQL Server, Oracle, or any other enterprise database, the behavior remains conceptually the same. The syntax may differ slightly, but the intention never changes. Transaction lifecycle is our next concept. Every transaction follows a clear and predictable lifecycle, even though the most users never see it happening. The lifecycle begins when a transaction starts. This may happen explicitly using begin or implicitly when auto commit is disabled. At this point, the database prepares itself to track changes rather than finalizing them. Next, SQL statements execute one by one. Insert, add rows, update, modifies values, and delete, removes records. Each change is carefully tracked internally by the database engine. During this phase, the database maintains enough information to undo everything if required. This is where transaction logs and internal buffers come into the play. Although those mechanisms usually remain hidden from the users, after all statements are executed, the transaction reaches a decision point. One of the two outcomes must occur. If everything is correct, commit is executed. The database permanently saves the changes and ends the transaction. If something goes wrong, rollback is executed. The database discards all the changes and returns to the previous stage. What is crucial here is that there is no third option. A transaction can never end in half-completed state. The database guarantees that it will either fully succeed or fully fail. This all or nothing behavior is what makes transactions more reliable. Why this lifecycle matters? Although this lifecycle is invisible to most users, it is absolutely critical behind the scenes. Every time you place an order, receive a salary, update customer information, generate financial reports, you are relying on this lifecycle to behave correctly. Understanding this flow not only helps you write safer SQL, but also helps you think like a system designer. It teaches you to anticipate failure, plan recovery, and respect data integrity. Now, with that, we make a transition to the asset property. Now, a quick introduction to asset properties and error handling in SQL. Now that we have built a strong understanding of transactions and we clearly know how begin, commit, and rollback work together, it's time we move into one of the most important theoretical foundations of SQL and database systems as a whole. This section is not just theory for the sake of theory. It explains why databases are trusted, why transactions work reliably, and why SQL systems can safely power critical business operations across the world. Every reliable transaction database follows a set of guarantees known as ACID or asset properties. Asset is not a buzzword. It is not any academic concept that exists only in textbooks. Asset is the reason why banks do not lose money, airlines do not double book seats, and enterprise can run large-scale systems with confidence. The word asset is an acronym, and each letter represents a functional fundamental property that a transaction must satisfy. A stands for atomicity, C stands for consistency, I stands for isolation, and D stands for durability. If you truly understand these four properties, you understand why databases are considered reliable systems rather than simple storage tools. Let's explore each one of them carefully, one at a time. First one is atomicity, all or nothing. Atomicity is often the earliest asset property to understand conceptually, but it is also one of the most powerful. Atomicity means that a transaction is treated as a single indivisible unit of work. In simple terms, a transaction must either complete entirely or not happen at all. There is no such thing as partial success. When a transaction contains multiple steps, the database does not allow some of them to succeed while others fail. Either all steps are applied successfully or every single change is undone. Imagine a transaction that contains 10 SQL statements. According to atomicity, the database guarantees one of the two outcomes. Either all 10 statements succeed or none of them are applied. There is no scenario where 5 succeed and 5 fail. This guarantee becomes especially important when systems fail unexpectedly. Consider what happens if a transaction is executing and the system crashes during the ninth step. From the user's perspective, this crash is unpredictable and unavoidable. However, the database still guarantees safety. It detects that the transaction did not complete fully and automatically rolls back all the changes made by that transaction. This is atomicity in action. Atomicity prevents half-written records from entering the database. It prevents partial updates that could break reports, analytics, or business workflows. It ensures that relationships between tables remain intact and logical. Without atomicity, databases would be extremely fragile systems. Every unexpected shutdown or error could leave the data in a corrupted or unusable state. Atomicity is one of the primary reasons databases are trusted in financial systems, healthcare platforms, airline booking engines, and other mission-critical applications. When money, lives, or legal obligations are involved, almost correct is not acceptable. Atomicity ensures correctness or nothing at all. Now, the next one, C for consistency. From one valid state to another, while atomicity focuses on all or nothing, consistency focuses on correctness. Consistency means that a transaction must move the database from one valid state to another valid state. A valid state is defined by the rules of the database and the rules of the business. These rules include technical constraints such as primary keys, foreign keys, unique constraints, and not null conditions. They also include business rules such as salary limits, account balances, or workflow conditions. For example, if a table requires that every employee must have a unique employee ID, consistency ensures that a transaction cannot insert duplicate IDs. If an order must reference a valid customer, consistency ensures that orders cannot exist without customers. When a transaction violates any of these rules, the database does not allow it to succeed. Instead, the transaction fails and is rolled back. Consistency ensures that invalid data never enters the system. It guarantees that every committed transaction leaves the database in a state that makes sense according to the defined rules. It's important to understand that consistency does not mean the database automatically knows what is right for your business. Instead, it enforces the rules that you, as a designer or developer, define. Once those rules are defined, consistency becomes the database's responsibility. This is why well-designed schemas matter. The stronger your constraints and rules, the stronger the consistency guarantees your database can provide. Consistency is what allows analytical teams to trust reports, auditors trust financial records, and engineers to trust system behavior. Now we have the next one, I for isolation, protection in a multi-user world. Modern databases are multi-user systems by design. At any given moment, hundreds or even thousands of transactions may be executing at the same time. Isolation answers a very important question. What happens when multiple transactions interact with the same data simultaneously? Isolation means that transactions should not interfere with each other in a way that causes incorrect or unpredictable results. In simple terms, isolation ensures that one user's incomplete transaction does not affect another user's transaction. Imagine one transaction is updating employee salaries, but it has not yet committed. At the same time, another user is running a report that calculates average salaries. Without isolation, the report might see half updated data, leading to incorrect results. Isolation prevents such scenarios. It ensures that uncommitted changes are not visible to other transactions. Dirty reads are avoided, data remains predictable and stable. Different databases implement isolation at different levels, allowing trade-offs between performance and strictness. These are known as isolation levels. While the strictness may vary, the core principle remains unchanged. Isolation exists to ensure that concurrency does not break correctness. Without isolation, databases would become chaotic under load. Reports would fluctuate unpredictably, updates would conflict, and debugging would become nearly impossible. Isolation is the silent guardian that allows multiple users to safely share the same database. Now comes the last one, D for durability. Once committed, always committed. Durability is the final asset property and it focuses on permanence. Durability means that once a transaction is committed, it will remain committed, even in the face of system failures. Once commit is executed successfully, the database guarantees that the data is safely stored. Even if the power goes out, the server crashes or the database restarts, the committed data will not be lost. This guarantee is achieved through internal mechanisms such as transaction logs, write-ahead logging, and persistent storage strategies. Before a transaction is considered committed, the database ensures that enough information has been written to disk to recover the changes if necessary. Durability is the reason databases can recover safely after crashes. When a database restarts, it replays committed transactions and discards incomplete ones. Without durability, a database crash could result in data loss, broken trust, and catastrophic failures. Durability transforms databases from temporary data stores into reliable systems of record. Why asset matters in real systems. At this point, it should be clear that asset properties are not abstract ideas meant only for exams or interviews. They are the foundation upon which real systems are built. Banks rely on asset to ensure financial accuracy. Airlines rely on asset to manage reservations without conflicts. E-commerce platforms rely on asset to synchronize orders, payments, and inventory. Enterprises rely on asset to run payroll, compliance systems, and analytics pipelines. When interviewers ask about asset properties, they are not testing memorization. They are testing whether you understand why databases can be trusted or not. A candidate who understands asset demonstrates system-level thinking, not just SQL syntax knowledge. Now we make a transition into error handling in SQL transactions. Now, let's move on from guarantee to reality. In the real world, errors are inevitable. Networks fail, constraints are violated, input is incorrect, applications contain bugs, systems crash unexpectedly, and the key question is not whether errors will happen. The key question is how databases handle these errors without compromising data integrity. The transactional system's error handling is deeply connected to asset properties. When an error occurs inside a transaction, the database does not panic or partially commit changes. Instead, it ensures safety. Errors typically trigger rollbacks. This means the database cancels all changes made by the transaction and returns to a stable state. Some databases automatically roll back when a fatal error occurs. Others require explicit rollback commands regardless of the implementation. The principle remains the same. Errors must never leave the database in an inconsistent state. This principle is non-negotiable in reliable systems. Now, the conceptual workflow of error handling. The conceptual workflow of error handling in transaction is simple and elegant. First, a transaction begins. Next, the SQL statements execute one by one. The database continuously monitors for errors. If an error occurs at any point, the transaction is rolled back. If all statements succeed, the transaction is committed. This flow is deeply embedded into enterprise systems, even if the developers are not consciously aware of it. It is this flow that allows databases to gracefully handle failures instead of amplifying it. This is why this chapter is career critical, and this chapter may feel theoretical, but it is one of the most practical chapters in SQL. Understanding transactions, asset properties, and error handling improves system design thinking. It prepares you for production environments. It helps you answer senior level interview questions with confidence. It builds credibility as a data professional. Many people know how to write SQL queries. A very few truly understand how databases behave under failure, load, or concurrency. This chapter closes that gap. Now, let's summarize everything that we have covered so far. Transactions group multiple SQL operations into a single logical unit of work. Begin starts tracking changes. Commit saves changes permanently. Rollback cancels all changes. Asset properties guarantee reliability. Error handling protects data integrity. Transactions form the backbone of enterprise systems. If SQL were a building, transaction could be its foundation. Without them, everything collapses. And that brings us to the end of this chapter. And now we transition to the next one. Let's imagine you just joined a company as a data analyst or a business analyst, and your manager gives you one of these CSV file and say, we sell products across multiple regions. We run marketing campaigns. We generate traffic, leads, and orders. And I want you to find the insights that can drive revenue and reduce losses. That's exactly what this project is all about. In this module, we will build a complete SQL sales analytics project using real-world sales data. We will move step by step, just like the actual analytics rule does. By the end of this project, you will know how to analyze sales data performance using SQL, how to convert raw data into business insights, how to write interview-ready SQL queries, how to explain your analysis like a professional data analyst. Now, before we get started with data understanding and everything, let me show you a quick way to understand how to import data. So this particular data is from an Excel workbook, just as we discussed. So it can be either an Excel workbook or it can be an Excel CSV file. So this is my data. So we'll be having order ID, order date, delivery date, order status, and all those things. So if you observe closely, on each and every column ID, I have not left any spaces. You can either go with an underscore or don't leave any space, because in real world data analysis, if you're having spaces in between the column header names, then you might face issues while writing the queries. So for safe side, just understand one thing: no spaces in between the column header names. Okay. And then make sure you save this as .csv, because in SQL workbook, we import data in the form of .csv files. So that's one major thing. Now, let me show you my data location. So we have data in the download section. Here we have the file. So if you save the same file in the form of .csv, this is how it's going to look like. There you go. And also you need to remember the files, the date files should be saved in the form of date, and the specific format should be year, month, and date, right? So let me go through the workbook and check if my data is according to my request. So here we have the data already. Let me also show you how to load it, not a worry. So there you go, we have the data in form of year, month, and date. So this is how you basically have the date files. So what I'm basically telling you is, before you load the data onto SQL workbook, when you have the opportunity to work on it on Excel, then why don't you use it, right? So most of the times, before you load the data, on any of the platforms. It can be a MySQL Workbench, or it can be a data visualization tools like Tableau, Power BI. Make sure you clean the data and data is ready for analysis, right? So we've already gone through how to, change the data type of the column, how to change some elements, how to replace filter and all those things, right? So based on that analysis or based on that approach, you might have to work on the data cleaning first. And once you're satisfied with it, you can close and load the data. So now back to MySQL Workbench. So this is the location. And now if you come back to the MySQL Workbench, now here you can see the databases. You can select any of the schemas. So this is my schema. So here what I'll do is I'll go for an option which says data import or visit, right? From here, I have already given my location, or else if your location is in a different location, then you can just browse and go to the location and then just select the file. And here you go to the next option, and here you have the next, right? So you already have the table. So in case if you don't want to delete the table and import a new one, you can just cancel it. But in case if you want, you are exploring, don't worry, this particular data set will also be provided to you in the description box below. And if you want to just load the data, you can just proceed with it. And I'll use the existing, so I don't want to delete the data table. So this is how you basically load the data table. And in case if you want a little bit more clarity, I'll also drop a tutorial link in the description box below, which will explain you how to load data from Excel files. So that's the approach. Just right click, and here you go to the table data import wizard and just select the location where you have it and then load the data. That's basically it. And once you are loaded the data, what you can do is select the database. I'll just use interview database, and then here show tables. So these are the tables you have, and this is our data set, which is sales data, and you have an overview. And once you load this data, you might be having a few errors on the column names, sometimes, very rarely, 1 out of 100 cases. So I had an issue due to some spacing issue on the name. So I quickly changed this, but let me expand this. Yeah, I quickly expanded or selected the column name. What I did is I just copy the field name and paste it over here. So this was the initial field name, and I changed it to my requirement, which is order ID. And once you do it, the column header name from this got changed to the expected name, which is order ID. And now we start with the business analysis and questions and queries, right? So this is how you quickly load the data to the MySQL Workbench platform, and then you start with the business queries. So this was a basic understanding of how to load the data and understand what's present in our data. Now let's proceed to deep dive into the data set. So now comes the data understanding. Before writing even a single SQL query, the first thing an analyst does is understand the data. Our dataset contains the following key information. We have order level data, which includes order ID, order date, and delivery date, order status, such as it is delivered or cancelled. We also have customer information, which includes customer ID, first name and the last name, which state or region he or she belongs to. Then comes the product and sales metrics, which includes product name, product category, product subcategory, the quantity of the product sold, cost of the company to make it, and the revenue details which we made out. And also we can have the profit column. And finally, the marketing funnel metrics, which include the traffic number on the website or the store's site, and the total number of leads we had, total number of orders we received, and all those things. This tells us something very important. This is not just sales data. This is sales plus marketing plus operations data all combined together, right? So we have the sales data, which has product price, cost of the company, revenue, and all those details. And we also have marketing data, which is about leads, revenue, and traffic, and all those orders, and the product data as well. So this is a combination of all three of the data sets together. And most of the times what happens is these three different data tables will be stored in three different data modules altogether. So we also had data modeling part in this particular full course. So you can go through that once again to get a full detail on this particular aspect, right? So most of the times the data will be stored in different tables so that we maintain a schema of data sets. Most importantly, we follow the star schema, and all the other tables are related to one another through a foreign key, right? Using foreign key, you can combine different tables to the fact table. So here the fact table will be the orders data table or the CS data table, and product data, marketing data, and all those things will be the dimension tables. But now to eliminate the confusion and keep the project more simplistic, we have combined all this together in one single data table, and we have it in one table here itself. So this means we can analyze revenue, profitability, conversion funnel, regional performance, product performance, order cancellation, and all those aspects in one single go. That's exactly what companies expect from SQL analysts today. Now, the project problem statement. Let's clearly define our project goal. So the problem statement is analyze sales, performance, profitability, and marketing efficiency across different regions, products, and customers to identify revenue drivers and business bottlenecks using SQL. It is simple, clear, and business focused. Now, let's get started with the questions and their answers. So the first question. So I have already added the questions here to save time and also the queries, and you can have this code documentation readily available for you in the description box below. So to follow up with me, make sure you copy the dataset and the queries document with you and be ready with your SQL workbench so that I will explain you on the go what's happening here, and you can also follow along with me and run the query with me and get the output. And if you're getting anything different or if you are facing any difficulty, please feel free to drop them in the comment section below and we will address that as soon as possible. Now, the first question is, what is the total revenue, total cost, and total profit? Let's understand this a little bit more detail before we start with the solution approach. So now what we are doing is we are understanding total revenue, cost, and profit, which is fundamental for any business. This analysis provides a snapshot of overall financial health of the company. Revenue indicates the total income generated from sales alone. Cost shows the total expenses incurred while manufacturing that particular product. And profit reflects the net gain. Now, monitoring these metrics helps decision makers evaluate the business performance and identify whether operational strategies are generating the desired financial outcomes or not. Now, let's go through the approach design, right? The query aggregates the values of revenue, cost to company, and profit across all records using a sum function. Each aggregation is labeled with an alias for clarity. For example, we have total revenue, total cost, and total profit. This approach ensures we get a single summary row representing the company's overall performance. Now, let's go through the query. So, as discussed, we have the sum of revenue and we have aliased it as total revenue. And total cost to company is aliased as total cost, and total profit is aliased as total profit as here, right? And you already know what is the meaning of aliases. It's just an alternate name or the user defined name for your column names or the output, right? So this was the indentation followed, but in case if you are someone like me who likes to have all the columns in one line and the table name and then get ahead with the indentation when you actually deep dive into queries, then this approach is fine for you. But in case if you are someone who is comfortable with naming the columns line by line, then you can follow the line by line approach. So this is the query that we will be executing now. So let's quickly execute this. And there you go. So you have all the details. So this is your total revenue, which is around 533 million. And the total cost is about 101 million. Or is it 10 million? I think, yeah. And then we have total profit. So this was the total cost we invested, and this is the total revenue we generated, and this is the total profit that we made. So this is how you go ahead with the first question. And now we come across the second analysis for the day. So the second analysis or the second question of the day is, what is the monthly revenue trend? Now, let's understand this question. So this question is basically about tracking monthly revenue trends that help businesses understand seasonality, sales growth, and revenue fluctuations over time. By visualizing these trends, organizations can identify peak periods, forecast future revenue, and make informed marketing or operational decisions. So it's basically like if you're going through a Diwali festival or Dasara or Christmas or any of the Eid or any of the special days like Independence, Republic, right? So you can take out the seasonality of that special occasion and then boost up the sales so that making those offers look more lucrative and make some more sale out of it. So that's the overall business perspective of this particular query. So it helps in evaluating the effectiveness of promotions and campaigns across different months. Now let's go through the approach. So this is the query. Now let's understand or deep dive into this particular query. The query uses date format function to extract year and month from order date and then groups the data by this formatted month. The sum of revenue function calculates the total revenue per month. Ordering by month ensures that the result set follows a chronological trend, making it easier to interpret temporal changes in revenue. Now, let's quickly execute this query and see the output. So here you have the date format, which extracts the year and month as provided here. So you have the percentage Y for year and percentage M for month, and it is aliased as month. And here you have sum of revenue, and we have aliased it as monthly revenue from the table, which is sales data. So this is another approach where you write the query. So here the column headers or the column names are mentioned in line by line. So you can also follow this one, this kind of indentation or this kind of indentation. Both are good enough based on your comfort, right? And then we are grouping by date format and ordering by month. Now let's quickly execute this query, and we will be using the shortcut method, which is Control Enter, and there you go. So we have date and month wise analysis. So here we have 2021 data starting and we are ending data with 2024. So this is the overall sales data, and here we have monthly revenue numbers. Now let's proceed with the next question, which is about which product categories generate the highest revenue. Now let's understand this question before getting started with the query. Now the third question is about which product categories generate the highest revenue. Now let's go through the explanation. Knowing which product categories contribute to the most revenue allows businesses to focus on high performing segments and optimize their product mix. It also helps in inventory planning, promotional strategies, and prioritizing resources towards categories with maximum financial impact. Now that was the backstory behind this particular query. Now let's go through the approach and query design. This query groups data by category, column, and calculates total revenue for each category using the sum of revenue function. The results are sorted in descending order to immediately highlight the top earning categories. This aggregation approach provides a clear ranking of categories based on their revenue contribution. Now, let's go through the query and understand what's happening here. So here, as discussed before, we have the following columns: category, sum of revenue, which is aliased as total revenue from sales database. And here we have category. We are grouping them by category and we are ordering in descending order so that highest revenue numbers comes on the top and the lowest revenue numbers comes below, right? Now let's quickly execute this particular query. We've also been through the group by and order by filters. So you can go through that in the previous chapters. And now let's execute this, and there you go. So the category FMCG, furniture, home appliances, clothing and electronics are the top revenue generators, and out of all those, FMCG is the highest revenue generator, almost next to the furniture. So you can next time, so you can focus on these two categories so that you can earn maximum benefits. Now let's go through the next question, which is about the top 10 products by profit. So the fourth question is about top 10 products by profit. Now what's the explanation for this particular approach? So identifying the most profitable products is crucial for maximizing business margins. While revenue indicates sales, volume, profit, it provides insight to the financial efficiency of the products. Highlighting top products by profit helps prioritize marketing, production, and strategic investment decisions. Now, this was the backstory for this particular question. Now let's understand how the query design and approach is for this particular question. The query first groups the records by product and calculates the total profit using sum of profit. Then we use order by to total profit in descending order and the products from the highest to lowest order. The limit 10, right? So we wanted to identify the highest number of products or the highest selling products, but we didn't have a limit here. So small improvement here. We want to find out the top 10 products, right? So if you want to find out the top n number of products, you can use limit clause and provide the n number. Let's say if you want top 5, then you can use limit 5. And in our case, we are using the limit 10 because we wanted to find out the top 10 products, right? So the limit 10 clause ensures only top 10 products are retrieved, giving a focused view of the most lucrative offerings. Now, let's go through the query and execute it. So here we have a product and sum of profit as total profit. And from sales data, we are grouping by product and order by total profit in descending order. And it is top 10, right? So limit 10. Enter. And there you go. So we have a washing machine, air conditioner, soap, headphones, and all the other top 10 products which are highest selling. So the next time in the marketing aspect, you can share this data with the marketing team so that they can run a couple of more ads and campaigns on washing machine, air conditioner, and soap so that by the end of the year, you'll have more profits in the upcoming sales analysis. Now, proceeding further, we have section B, which is about the customer analytics. And here, the first question or the overall fifth question that we are facing is, how many unique customers do we have? Now, let's go through the question a little bit more. So to deep dive how many unique customers we have, we are basically here trying to understand the size of customer base, and it is very vital for any business. It is vital for assessing marketing research and growth potential as well. Knowing the number of unique customers helps you segmenting audiences, target retention campaigns, and estimating lifetime value per customer. It also serves as a foundation for analyzing repeat business and customer loyalty. Now that we have a briefing on why this particular question is placed, let's go through the query approach and design. The query uses count of distinct of customer ID. So this is a part. So basically we have two aggregate functions here, the count function as well as the distinct function here to calculate the number of unique customers. This ensures that even if a customer has placed multiple orders, they are only counted once. This approach provides an accurate representation of the business actual customer base. Now, let's go through the explanation. So here, as discussed, we have distinct. First, we are filtering out the customer so that the customer ID is unique. There are multiple possibilities where one customer ID could have placed multiple orders, right? So multiple entries in rows. So what we're doing here is basically you're finding one repetition of each customer, and then we are counting the total number of customers and aliasing them as total customers. And then we are selecting this from sales data. So let's quickly run this query, and there you go. We have about 3,216 unique customers in our data set, and these might have place multiple orders. So the overall count of rows could be a little different. Now, let's proceed with the next question in our customer related queries. So the next question is, which states contribute to the most revenue? So let's deep dive into this question a little bit more. So identifying revenue contribution by state helps businesses understand the geographical performance. It highlights high performing regions that can be targeted for growth and underperforming states that may need marketing support or operational improvements. This analysis is crucial for regional strategy, distribution planning, and resource allocation. Now that we have a brief understanding of why this question was asked, let's go through the query approach and query design. So this is our query. Let's understand this a little bit. The query groups sales records by the state column and sums the revenue of each state using the sum of revenue function. Results are ordered in descending order of revenue to immediately identify top performing states. This aggregation approach provides a clear picture of geographical revenue distribution. Now let's quickly run the query and see the output. So as discussed, we have state here and sum of revenue as total revenue alias and table name.
So we are here trying to perform a group by function, and we are ordering revenue in descending order. And in case if you are having that question, can we find out the top 5 performing states? Yes, we can just limit them by 5, and we will have top 5 states here: Telangana, Odisha, Delhi, Maharashtra, and Kerala. And if you remove this particular limit function, you will have the entire states list right here, right? So all the states and their performance. Now with that, let's go to the next question, which is the 7th question and 3rd question in customer analytics. So here we are trying to find out average revenue per customer. Before we execute this query, let's go through a little bit more deep dive into this particular question and why this was being asked from an interview perspective. So average revenue per customer. Why this question is asked? Average revenue per customer, or in short, ARPC, measures the value each customer brings to the business. It is an essential metric for evaluating customer profitability and effectiveness of sales or marketing strategies. Higher ARPC indicates better monetization on the customer base and helps in targeting premium customers. Now that we have an understanding why this question is being asked, let's go through the approach in solving this question and the query design. The query groups data by customer ID and calculates the average revenue using average revenue function. This approach ensures that we get per customer data view of revenue and highlighting differences in spending patterns across the customer base. Now, let's go through the query and execute this. So as discussed, we have customer ID, average revenue as average revenue per customer aliases, and we are grouping by customer ID. Now, let's execute this query and see the output. So here, based on their revenue, here we have the highest spending or the average spending of each customer, right? So there are a few customers who have been registered onto the website, but so far they haven't made any sale or purchase from our website. And apart from that, we also have a few customers which have already placed some orders, and there are a few customers who are repeated, and there are a few premium customers as well with the highest number of sales from the website. Now, we enter into the next section of this particular project, which is about regional performance analysis. So in the regional performance analysis, we have the 8th question, or the first question in this particular part, which is about revenue contribution by region. So let me scroll this a little. This is our question and the query. Now let's go through the question and understand a little more detail why this question is being asked. Now, revenue contribution by region is very important. Regional revenue analysis provides insight into which areas generate the most income. This helps in strategic planning for expansion, marketing campaigns, and allocation of sales resources. It also identifies strong and weak regions to improve operational efficiency. Now that we have a briefing on why this question is being asked, let's go through the approach on what basis this question can be solved and the query design. The query groups the dataset by region and sums the revenue column. This aggregation ensures each region total revenue is calculated, providing a concise overview of regional performance. Now, let's go through the query and execute this. So as discussed, we will be having region and summation of revenue and alias as total revenue from sales data, and we are grouping by region. Now let's execute this query, and there you go. So we have overall country-wise East region sales revenue, West region, Central region, South, as well as North. So region-wise, these are the sales numbers. Now, let's dive into the next question, which is about profit margin by region. So this is our question and query. Before we execute the query, let's understand what is the meaning of this question, or what's the reason behind this question, and understand the query approach and design. So profit margin by region is really important. Understanding profit margins at the regional level helps businesses assess operational efficiency and pricing effectiveness. A region might have high revenue but low profit margins. This indicates cost ineffectiveness or discounts impacting profitability. Now, this was the reason behind why this question was asked. Now let's discuss the approach to solve this question and what is the query design. The query calculates profit margin using the formula, which is sum of total profit divided by sum of total revenue into 100, which is named as profit margin or alias as profit margin from sales data. And we will also be using a filter function here where revenue should be greater than 0, which ensures division by 0 is avoided. Now, along with that, we will be using a round function, which enhances the readability of percentages. Now, let's go through the query and execute this. So here we have it. So we are selecting the region column, and then here is the function or the mathematical calculation, and we are aliasing it as profit margin percentage from sales data. This is the filter that we were talking about. Revenue should be at least greater than 0, right? And you can have at least 1% revenue, but it shouldn't be 0. That's why we have using this filter, and we are grouping by region. Now let's execute this query and see the output. There you go. So we have East region profit percentage margin, South, North, West, Central, so on. So these are the profit margins here. Now we dive into the next section, which is marketing funnel analytics. Let me point this out. This is very strong analytical section and great for interviews. And in this, the first question we have is traffic to lead conversion. Most of the times, if you are a business analysis aspirant or a data analysis aspirant, or you're already working in business analytics or data analytics, then these are the most common figures that you will be listening or saying in your meetings. Traffic to lead conversion, lead to order conversion, right? So these are some important things that you go through in interviews or in a business analyst day-to-day life, right? So this is one such question, traffic to lead conversion rate. Now, let's understand the business aspect behind this particular question. And along with that, we'll also see why this question was being asked and what's the solution to this particular question and what's the design of the query. So traffic to lead conversion is critical. Conversion from website or store traffic to leads show how effectively marketing channels are capturing potential customers. This metric helps evaluate campaign efficiency and the quality of the visitor engagement, forming a critical part of marketing analytics. Now, let's go through the approach to solving this question and also the query design. The query sums the total leads and traffic across all records and calculates the conversion rate as leads divided by traffic into 100. And we also use a round function to format the percentage. Aggregation across the dataset provides an overall conversion insight. Now, let's go through the query and execute this. So, as discussed, we will have the function sum of leads divided by sum of traffic into 100, and we are giving a round function as well. So, we are rounding up the decimal values to 2 decimal values, right? So, this is the total function here. And we are aliasing it as traffic to leads conversion percentage, and we are selecting this data from sales data, right? So let's execute the query, and here we have the output. So traffic to lead conversion is 10%, which is pretty decent. Now, along with that, let's go to the second question, which is about lead to order conversion, right? So the traffic will be on your website, and if your marketing is really good, then they convert into a lead which show interest in your product, right? And we want that lead to convert into an order. That's the critical point, right? So this is the intention behind asking this question. Anyways, let's deep dive, right? And after that, we'll also go through the approach. Lead to order conversion indicates the effectiveness of sales process. It measures how potential customers, basically leads, are successfully converted into paying customers which place an actual order. This is basically done for highlighting areas for sales optimization. Now let's understand the approach to solve this question and the query design. The query sums orders and leads where leads exist and calculate them as orders divided by leads into 100. We also use a where clause as a filter where it filters down the leads having number greater than 0, and this condition avoids division by 0 errors and ensures the calculation is meaningful for relevant data points. Now, let's go through the query and see the output. So this is where we had the total orders divided by total leads into 100. And we also have the round function here where we will have the decimal values limited to 2 numbers, and we are aliasing it as lead to order conversion. And leads filter here, it should be greater than 0. Now, let's execute this query and see the output. So lead to order conversion is somewhere around 0.9%. Now, with that, let's move into the next question, which is about overall funnel conversion. So traffic to order is this particular aspect. Now let's go through the intention behind asking this question. Traffic to order is also one of the important aspects. The overall funnel conversion rate reflects the efficiency of the entire marketing and sales process. From attracting traffic to closing orders, it's crucial for evaluating end-to-end performance and return on investment of campaigns. Now, let's go through the approach to solve this question and query design. The query aggregates total orders and traffic and calculates orders divided by traffic into 100. This approach summarizes the overall funnel efficiency, giving leadership a clear metric of conversion effectiveness. Now, let's go through the query. So here we have it. So we will be dividing total orders divided by total traffic and into 100, and here we have a round function as well to limit the decimal values to 2, and we are aliasing it as overall conversion rate from sales data. So let's quickly execute this query to see the output. So overall conversion rate is somewhere around 0.09%. So this is some serious issue. So we need to focus more on sales and marketing. Don't worry, this is not a real sales data. This is an actual data which we created for learning purposes, right? So the real business data might vary a lot, but it could be also a reality where the conversion rate is really falling and you need to focus on improving, right? In the initial stages, any business might have weak performances, but down the line, if you are someone who's really good with analytics, then you can help the company to grow, right? That's the overall perspective. Now, let's dive into the next question, which is about funnel performance by category. So why this particular question is being asked? Now let's go through that. Analyzing conversion by product category helps identify which product lines convert visitors into buyers most effectively. This insight guides marketing focus, inventory allocation, and promotional strategies. Now that we understand why this question is being asked, let's go through the approach to solving this question and the query design. The query groups data by category and calculates conversion as total orders divided by total traffic into 100. Using grouped aggregation allows comparing performance across categories and identifying high and low performing segments. Now, let's execute the query. So as discussed, we have the category and the function of total orders divided by total traffic into 100. And we are rounding this particular number as 2 decimal values using the round function, and we are aliasing it as conversion rate. And we're extracting this data from sales data and we're grouping by category. Now, let's quickly execute this query. So we have electronics, clothing, home appliances, FMCG, furniture. So far we have furniture and FMCG as the highest performing categories, and the conversion here is really good. Now, rest of them needs a little more attention. And with that, we enter the 5th segment of this particular analytics, which is order and operations analysis. And that we have the 14th question as our first question, and it is about order status distribution. Now, let's deep dive what's the meaning of this question, and along with it, we'll also go through the solution approach and the query design for this question. So order status distribution is really important as well. Understanding the distribution of order statuses, which is delivered, pending, cancelled, etc., provides visibility into operation performance and customer satisfaction. It highlights bottlenecks and potential service issues. Now that we have a brief understanding of the question, let's go through the approach in solving this question and the query design. The query here basically groups by order status and counts the number of orders per status using count star function. This gives a simple frequency distribution, making operational insights easy to interpret. Now, let's go through the query and execute it. So as discussed, we have the order status and we are counting the total number of orders, and we are aliasing it as total orders from sales data grouped by order status. So we might be having a delivered, cancelled, pending, something like that, right? Based on that, we will be grouping it. So we have 997 delivered, 986 cancelled, and 1013 written, and 980 pending. So these are the statuses of our products so far. Now that let's dive into the next question, which is average delivery time for delivered orders. So if you go back to the dataset, you might have seen order date, delivered date, and as well as we have created another column which says time to be delivered, right? So it is basically the time difference between delivered date and ordered date. Let's say we have 5 days of difference between the order date and delivered date. So we are trying to, okay, before we solve this question, let's understand why this question is being asked and what's the query design, right? That is the basic approach. Before you start to write any query, you need to understand the question. And if only you understand the question, then only you can design a perfect query for that. So let's understand the question. So average delivery time for delivered orders is basically measuring average delivery time that helps evaluate logistics efficiency and customer satisfaction. Faster deliveries usually correlate with better customer experience and retention. Now, let's understand the solution approach and query design. The query calculates the average difference between delivery date and order date using the average date diff function. For orders marked as delivered, filtering ensures only relevant orders which are completed are included and rest are ignored. Now, let's go through that. So here we, before, the previous question, we had cancelled, return and pending, right? So here we are specifically filtering out the delivered products only, right? So once we have the data of delivered orders, and based on that, we can find out the order date and delivery date of that particular product and find the difference. And once the difference is found, we will have multiple rows of number of dates, and that particular rows will be filtered out using an average function, right? Let's consider 10 rows. One product might have taken 5 days to deliver, one might have taken 3 days, one might have taken 2 days, one might have even taken 7 days, right? So out of all those 10 entries, we will find out an average of 10 days, 7 days, 3 days, 6 days, etc. And then we will have a final number. So you can declare that as this is the average time that we are taking to deliver one product to a customer. Now let's execute this query, and there you go. So on an average, we are taking about a 5.99, or we can consider 6 days on an average to deliver any product from the inventory to the customer. So on the application or on the website, you can confidently mention within 6 days, your product will be delivered to you, right? Now that may help you in retention, right? So customer might feel happy that within 6 days, I'll be receiving this product. That's the basic approach behind this question. Now we have the question which says or speaks about cancellation rate, right? Now, why this question is being asked and how do we solve this? Let's understand that. Cancellation rate measures the proportion of orders that did not complete successfully. High cancellation rates indicate potential operational issues, product dissatisfaction, or a pricing problem. Now that we have understood the concern behind this question, let's understand the approach to solve this question and the query design. The query counts cancelled orders using a case statement inside sum function and divides by total orders. Next comes the round function, which formats the result as a percentage, giving a clear view of order cancellations. Now that we have a clear understanding of how this question can be solved, let's go through the query and solve this particular question. Here, let's dive with this particular case. So we are using cases here. Now, when case order status is cancelled, then 1, else 0. So in the previous chapters, we've also been through cases. And this gets divided by count of staff into 100. And the decimal value is limited to 2 numbers. And this is aliased as cancelled rate. And now let's execute this query. There you go. So the average cancellation rate we have is 24% as of now, which can be reduced based on improving the product quality and decreasing the days to deliver and basic things that we discussed now, right? Now, let's go ahead with the next question, which is the 17th question. And a new section is also allocated here, which is about profitability analysis. Now, in this particular profitability analysis section, the first question we have is profit margin by product category. Now, let's understand the question. Profit margin by product category is basically about evaluating profit margin by product category, which helps identify high margin product versus a low margin category or product. This informs pricing strategies, product focus, and profitability optimization. Now that we have a briefing on the question, let's go through the approach to solving this question and the query design. The query groups by category and calculates the total profit divided by total revenue into 100. And we will be filtering out by revenue, which should be greater than 0, which avoids invalid calculations. And finally, we'll have a round functions, which ensures clarity in presentation. Now that we have a briefing on the approach, let's go through the query and execute this. Now we are trying to find out the profit margin by dividing the total profit by total revenue. And we have a round function to minimize the decimal values to 2. And we are aliasing it as profit margin. And here you see we are filtering out the revenue should be greater than 0 and we are grouping by category. Now let's quickly execute this query and see the output. So here we have all the categories and their profit margins as well. And you can also add another query which is order by descending. So we have FMCG on top and the rest of them in following in the next, right? We have clothing in the next section, home appliances in the next section, and so on. Now we have the next question, which is the 18th question in this section, which is about loss-making products. Now let's go through the intention behind asking this question. So loss-making products is nothing but identifying the products that generate a little or negative profit. This helps businesses optimize their portfolio by removing or repositioning loss-making products, and this can make significant improvement in overall profitability. Now we have understood the intention behind this question. Let's understand the approach to solving this question and the query design. The query basically groups by product and sums profit, and we are using having by clause where the total profit should be less than 10. And this filters the underperforming products. This approach directly highlights the items contributing minimally or negatively to profits. Now that we have a briefing on the approach, let's go to the query and solve the question. Now, as discussed, we have the sum of profit from sales data, and the filter having profit less than 10 is the filter or the query here. And now let's execute the question. So far, there are minimum products which are underperforming, those, or you can also change to 2 and find out if there are any products which are even now. So it's good enough. Maximum number of products that we have in our inventory are not underperforming, right? So that's a good news. Now with that, we enter into the next section, which is advanced analytics, and it makes you a little ready for interviews. Now inside that, we have about 2 questions more, and out of which the first one is top 5 customers by lifetime value. What does this question mean? Now let's highlight the query and understand what's the intention behind this question. So top 5 customers by lifetime basically means the lifetime value or LTV, which qualifies the total revenue as a customer brings over time. Identifying top customers by LTV helps prioritize retention, loyalty programs, and personalized marketing strategies. Now that we understand the intention behind this question, let's go through the approach and query design to solve this question. The query groups by customer ID, sums revenue per customer, orders the results by lifetime value in descending order, and limits the output to top 5 customers. This highlights the highest value customers most efficiently. Now that we have understood the approach, let's go back to the query and execute this. So here we have minimum customers. Yeah. So these are your high value customers, which gave you about so much revenue. 1,71,000, 140,000, 120,000, 117,000, and 117,000. So these are the top 5 customers which have your highest lifetime value. So here we have the sum of revenue as lifetime value and customer ID. And we are grouping by customer ID, and we are ordering lifetime value in descending order. And we have the limit 5, right? So which reduces or filters out the top 5 performing customers. Now we have the last question in this particular project and the second and last question in this particular section of advanced analytics. So this question is about repeat customers versus one-time customers. Now, what do you mean by repeat customers versus one-time customers? So let's understand this question. So repeat customers versus one-time customers differentiates repeat and one-time customers is crucial for retention analysis. Repeat customers indicate loyalty, while one-time or high one-time orders may point to marketing but weak retention. Now, this was the intention behind the question. Now, let's go through the approach in solving this question and the query design. The query first calculates order counts per customer in a subquery. Using a case statement, it classifies customers into repeat or one-time, grouping the customer type, and counting provides a clear comparative distribution. Now, let's go through the query and execute it. As discussed, we have case statement here. So if the order count is greater than 1, then it is referred as repeated customer. Else, it is referred as one-time customer. And the case ends here, right? And now we will count the total number of repeated customer and we'll also count the total number of one-time customers. And from there, we will select the customer ID, order count, and then we group by customer ID, right? So this particular query is encapsulated inside an outer query. So this is the inside query and this is the outside query. So if you have any doubts in subqueries, you can go back to the subqueries chapter and go through that once again. Now, finally, we will group by the customer type and then we will have the total number of repeated customers and the total number of one-time customers. So let's quickly execute this query. So there you go. We have 2,574 one-time customers and 642 repeated customers. And that brings us to the end of this session on the SQL data analysis project. And now we will proceed to the next section. Now we enter module 13, which is basically about framing SQL as an analytics tool. Up until now, we have been using SQL primarily to fetch data. But in this chapter, we will shift our focus. We are going to use SQL as a powerful tool for analysis. This is the difference between someone who knows SQL syntax versus someone who can drive business decisions using SQL. So, what does data analysis in SQL really mean? It's about comparing values to identify patterns, creating categories for better insights, ranking records to spot top performers or priorities, tracking change over time to understanding trends, finding patterns directly in SQL without exporting to Excel. This chapter is essential for anyone in analytics roles, including data analysts, business analysts, product analysts, BI developers, writing analytics queries, and a lot more. Now, let's get started with what is an analytical query. An analytical query is more than just fetching data. It is designed to aggregate information, compare results across groups, identify trends and patterns, answer why something is happening, not just what is happening. For example, you might want to ask who are the top performers in my company? Which customers bring the most value? How is revenue changing day by day? Now that we have understood the basic fundamentals of this particular chapter, let's get started with the analytical queries. Now, starting with the first one. Salary analysis, and the business question here is, what is the average salary per department? Now, here we will understand the group by, which allows us to define the level at which we want to analyze the data. The aggregation functions like average convert raw rows into meaningful insights. Now that we have the basic understanding, let's go through the query. Now here, this was our first analytical query, which asks one question: what is the average salary per department? Let me expand this particular area. Yeah. So here, what we're trying to do is we are trying to identify the department name, and we're using the average aggregate method to identify the average salary, and we're aliasing this as average salary. And we're extracting this from the employees table E, and we are trying to join with departments table D, and we are joining the tables based on the department ID from employees table and departments table, and we are grouping by department name, right? So based on this query, we will be getting the department names in the table and their average salaries. Now, let's quickly execute this query and see the output. Now, based on the query, we are having HR as 60,000 average salary, engineering as 1,08,000 as average salary, finance as 95,000, and marketing as 80,000. Now, let's go into the second analytical query, which is about how many employees were hired per month. Now, let's understand the question here first. So, business question here is how many employees were hired in each month? The real world relevance. This analysis is used in HR planning and workforce forecasting. Now that we have understood why is this particular question is being asked, let's solve this. Now in the query, we have date format. Here, we are extracting percentage %y, which stands for year, and percentage %m, which stands for m. Now based on this, we are hiring employees and we are using count star, and we are aliasing this as hires, and here we are aliasing the date format as hire month. And we are grouping by hire month and order by hire month. Now, let's execute this query, and there you go. And in case you want to, uh, order by, add some more value to this, you can order by descending, and which gives you December and November were the highest hiring months, and this is our answer. And now let's proceed with the next analytical query, which is right here on my screen, customer order frequency. Before we execute this query, let's understand the key aspect, why this is a question here and how do we solve this. So customer order frequency basically gives one business question. How often do our customers place orders? Now, what's the business meaning? This query helps identify repeated customers, which is critical for designing loyalty campaigns. Now, let's go to the query. Here we have the query, and here we have the customer ID count as star as total orders from orders data table, and we are grouping by customer ID and order by total orders in descending order. So once we execute this query, here we have our output. So these are the customers and their total orders. Customer number 2 is a repeated customer and the total orders placed by him or her are 4. Next is customer ID 1 and he or she placed 3 orders and so on. Now we get into another example, which is case example salary banding. Now the business need clarify the employees into salary ranges or classify the employees into salary ranges. Let's select the query. This is our query. Now let's understand the intention behind this query. Using case statements in select. So what is a case in SQL? Think of case as a SQL's version of if-else logic. It allows us to create categories, apply business rules, convert numeric values into readable labels. Now, case example, salary banding. Now, what is the business need here? We need to classify employees into salary ranges. Why analysts love case? So we have some answers for that. It eliminates the need for pre-processing. You can perform clean categorization directly inside SQL. Now let's go through the code. So here we have the case. So when salary is greater than or equals to 1 lakh, then deem it as high. And when salary is greater than or equals to 70, then deem it as medium, else consider it as low. And the case ends here. So this is our case statement. And we will alias this case as salary band. And we will be extracting name of the employee, salary details of the employee, and the case result of the employee from the employee's data table. Now, let's execute this query and see the output. So we have Alice, Bob, Charlie, David, and Eve, and their salary numbers, and their salary band falls in medium, high, so on, as described in the case statement here. So Frank is having low salary, and Ivan is having low salary, or in case of low, you can also tag them as new recruits or freshers or interns, right? Now with that, let's move into another example for case, which is department-wise salary labels, which is basically a similar approach, right? But still, let's go through the question once again. So the example 2, which we have about department-wise salary labels, which is basically none other than the same question. So let's go through the query here once again. But there are a few differences. In case of salaries, we have the department-wise details here. If department ID is equals to 2, then tech department, department 1 is equals to support department and others, right? So this query is basically designed just so that you understand how case actually works in real time, right? Now let's execute this query and see the output. So here we have the same name of the employee, department ID. And if the department ID is 2, then we have the tech department. If it is 1, then the support department. If it is anything other than the tech and support, like marketing, software engineering, etc., we will deem it as other, right? There you go. Now let's also go through another example in case so that we have a comfortable understanding. So here the example is about customer segmentation. Now, what's the business aspect of finding out this particular answer? Now, let's go through that. Let's select or highlight the query first. So what's the business question, right? Which customers are high value and what's the industry usage? It is used in CRM segmentation, marketing target, and revenue prioritization. Now, let's go through the query. So here we have the case statement. So this particular one is the case statement where count is greater than 4 or greater than or equal to 4 and it is high value customer, greater than or equal to 2 then medium value customer. If it is greater than or equal to 1 or less than low value customer. This is aliased as customer segment and we are counting the total orders here and the customer ID. We're extracting the customer ID from orders table and group by customer ID. Now, let's execute this query. Control enter. And here we have the customer ID and total number of orders they have placed. So if it is greater than or equal to 4, high value, greater than equal to 2, then it is medium value. And the other one is else low value, right? So this is how you execute the customer retention things, right? Now we have the next function, which is a row number. Now out of which one example is rank employees by salary per department. Let's highlight the query first and then understand the intention behind this function and how do we use it. So before we move into the next function, which is row number, I want to quickly deliver one interview tip for you. So if ever someone asks you about to explain about case, then consider two things, right? The bad explanation of case could be this one. Case just replaces if. No. Yeah, I agree that I told if is a replacement for case in SQL, but there is a difference, right? It was given for a quick understanding of the difference. But in interviews, that's the reason why I'm giving this tip to you. In interviews, when someone asks you to explain about case in SQL, then you can go with this strong explanation where instead of just saying it as a replacement for if, you can say case enables rule-based categorization directly in SQL query. If you have gone through our codes here, you can see we have different categories, right? If there is something happening in the dataset, then deem it as or categorize it as under this particular value. And similarly, if something is happening here, category in this particular aspect, and so on, right? So it is just another categorization tool where it compares the values and based on the results, it categorizes. This is the perfect and strong explanation of case in interviews. Remember that. So in the beginning, we said it is just a replacement for if. It is just said so that you have a quick understanding. It's not the final answer. Remember this. Now we enter window functions, which is the core of data analytics. Now, what are window functions? Window functions allow you to perform calculations across related rows without collapsing the data, unlike group by. Why window functions matter is your next question. Now, without window functions, you often need complex subqueries and multiple joins, which hurt performance. With them, your queries get cleaner, faster, and more readable. So one such window function is row number. Now, what does row number function do? It assigns a unique sequence number within a group. For example, rank employees by salary per department. Now, what's the business usage of this particular question? It identifies top performers duplicating records, picking the latest records. Now, let's go through a sample query here. So here on my screen, you can see a sample query where we are selecting the customer ID. They're counting them as total orders. Okay, this was a previous query. Yeah, here we have the row number. So this was the example, rank employees by salary per department, right? So here we have the employee ID, employee name, department ID, and their salary. And here we have the row number function over partition by department ID, order by salary descending as salary rank from employees. Now let's quickly execute this query and there you go. So based on salary numbers, we have rank 1 and 2 and 3, 4 and so on, right? Now we will have a quick comparison between rank function and dense rank function. And we'll also go through an example which says department salary ranking. Now let's highlight the query and then we will try to understand the business requirement or business behind this particular functions. Department salary ranking, right? Rank skips the numbers if there's a tie. Dense rank, on the other hand, does not skip any numbers. That's the basic difference between rank and dense rank. Now, let's execute this query and see the output. So there you go. So there are no rank gaps like we had in the rank, right? Here in the dense rank, we don't have those gaps. Now we have another window function, which is lag function. It assesses previous row data. And we also have a quick example for this here, day over day sales comparison. Let's highlight the query. Now, let's understand the business behind this function. Lag method assesses data from a previous row. For example, day over day sales comparison. Now the business insight. Growth analysis trend is one business insight where you can implement the lag method. Now let's go through the example. So here we have the lag amount over the order by date and the previous day sales. Now let's execute this query and see the output. Now the daily changes are written in the last column and the previous day sales are here and the total amount is here. Now the next function is lead, which is assesses next row data. Now let's highlight the query. Now what is lead method? It assesses data from the next row. What's the use case? It is used in predictive comparisons, performance tracking, and much more. Now here we have a query for quick understanding. And let's execute this. And there we have the output. Now the last one in this particular segment is the running total. So running total window function, which is basically from advanced analytics. Let's highlight the query and now understand the business insight of this particular window function. So this particular window function is used in financial dashboards, KPI tracking, investor reporting, and a lot more. Let's quickly execute this query and see the output. There you go. So we have the outputs over here. Now let's have a quick follow-up of all the window functions. Case statements, window functions, analytical thinking in SQL. You are no longer a beginner. This chapter prepares you for data analyst interviews, building business dashboards, solving real-world analytics problems, and a lot more. With that, we have come to an end of this module, and now we transition to the next module. So the first question is, what is the difference between SQL and DBMS? To understand this question at a professional level, learners must internalize that SQL and DBMS serve two completely different roles, yet they work together tightly. SQL, or structured query language, is a standard communication language. It is the vocabulary and grammar we use to talk to a database. We can write select star from customers. We are simply sending a request. We don't actually store data using SQL. We don't manage files using SQL. We don't enforce security using SQL. All of that is the job of DBMS. A DBMS, or database management system, is a fully fledged software that handles how data is stored internally, how it is indexed, how users access it, how security rules are applied, how concurrency is handled, how backups and recovery work. So SQL is just the language, while DBMS is the system that understands and executes that language. So a helpful analogy, SQL is the remote control and DBMS is the TV that responds to the button presses. Without TV, the remote accomplishes nothing. Without remote, the TV cannot receive instructions. Now let's go through some examples to strengthen the understanding of SQL Server. SQL Server uses eSQL, Oracle uses PL SQL, PostgreSQL uses PostgreSQL SQL, Dialect MySQL uses its own SQL variant. So SQL sits inside a DBMS the same way a steering wheel sits inside the car. It's necessary, but not enough to make the car move. Now, the second question. Explain primary key versus unique key. This question helps interviewers assess whether you understand how relational databases maintain identity and prevent duplicate records. A primary key is the central identifier for a row. It is the official identity card of each record. Before that, a primary key must meet two conditions. The first condition is uniqueness. No two rows can share the same ID. Second one, not null or non-null. Every record must have an identity. A unique key, on the other hand, enforces uniqueness but does not define the identity. It's more of a constraint that ensures no duplicates are allowed here. So the key difference is primary key is equals to strict, no duplicates, no nulls, only one per table. On the other hand, unique key is equals to flexible, no duplicates, allows a single, multiple allowed tables analogy. On the other hand, unique key which is equals to flexible, no duplicates allowed, a single null, multiple allowed. Now let's go through a table analogy. Imagine a table analogy. Imagine a table called employees. Primary key is employee ID, unique keys are email, phone number, and every employee must have an ID. But emails simply must be unique to avoid any conflicts. This distinction keeps data clean, consistent, and logically structured. With that, we move into the next question. What is a foreign key and why is it important? A foreign key is the glue that holds relation databases together. It connects tables exactly the way real-world relationships links entities. A foreign key in one table refers to primary key in another. This enforces referential integrity, meaning you cannot insert an order for a non-existing customer. You cannot delete a customer still referenced by others. You cannot break relationship chains accidentally. Now let's go to a real-world analogy. An order referencing a customer is a passport referencing a citizen. The relation must be valid. Without foreign keys, datasets become chaotic. Broken relationships, missing references, incorrect reports, often records, foreign keys keep the database accurate, safe, and logically consistent. Now, the fourth question, difference between where and having. Now, this is one of the most commonly tested SQL concepts because it checks your understanding of query execution order. Let's start with where. Where clause filters rows and applies before the group by function. It cannot use any aggregate functions. For example, where salary is greater than 50,000. Having clause, on the other hand, filters groups after group by function is applied. It can go with aggregate functions. For example, having count greater than 3. Now, let's have a mental model mapping. Imagine organizing employees by department. Where clause filters individual employees before grouping. On the other hand, group by forms the groups. Next is having clause. Having filters the groups themselves. This conceptual clarity helps avoid mistakes in analytical SQL. With that, we jump into the question number 5. The question number 5 is about the difference between inner join versus the left join. Joins reveal how well someone understands relational thinking. Inner join returns rows only when both tables have matching values. Left join returns all rows from the left table and matching rows from the right table. Missing matches become null. Now, let's have a mental visualization. Let's have a Venn diagram. Inner join is equals to intersection. Left join is equals to entire left circle with intersection. Now, let's go through a practical example. For inner join, let's consider customers who made some purchase. For left join, all customers, including those with zero purchase. This distinction is essential for building BI dashboards, performing retention analysis, or generating financial summaries. Now, let's dive into the question number 6. What is normalization? Normalization is the process of structuring data to reduce redundancy and improve consistency. So, we have a few types of normalization. So, the first one is 1NF, no repeating groups. So, atomic only values are stored here. The second one is 2NF. It must be in 1NF, removes practical dependencies. The third one is 3NF, must be in 2NF and removes transitive dependencies. Why normalization matters? Normalized data avoids duplicate information, updates anomalies, inserts anomalies, deletes anomalies. So, the database remains scalable, clean, and reliable. Now, let's enter into the question number 7. What is denormalization? While normalization focuses on structure, denormalization focuses on performance. It intentionally introduces redundancy to reduce joins, lookups, computation time. And now comes the question where it is used. It is used in data warehouses, BI reporting, OLAP, star schemas, etc. Now let's consider a small analogy. Normalized is equals to highly organized data library. Denormalized is equals to popular books placed at the entrance for quick access. You trade structure for speed. Now we have the 8th question. What is a subquery? The answer, a subquery is simply a query inside another query. It is used to answer more complex questions. Where subqueries help is your next question. It helps in dynamic filtering, ranking, and comparisons. Apart from that, it is also used in conditional validation, nested logic, and a lot more. A few examples to consider: finding second highest salary, checking if a value exists in another table or not, filtering based on aggregated criteria. Subqueries increase the expressive power of SQL dramatically. And with that, we dive into the question number 9. What is an index and why is it used? Indexes are crucial for database performance. Let's go through an analogy. Think of an index page in a book. It helps you jump directly into the right content instead of flipping every page. What indexes do? Indexes accelerate select queries, improve filtering and joins, enable fast ordering and grouping, but they come with a cost. Slower inserts, updates, because index must be updated. Increased storage usage. Indexes are one of the first performance optimization tools. Every SQL developer must understand them. Now, with that, let's dive into the question number 10. Question number 10 is, what is ACID compliance? ACID, or simply called as atomicity, consistency, isolation, and durability for the full form. It ensures reliability and predictable transaction processing. Atomicity is the first one. All steps succeed or none do. Second one, consistency. The database remains valid after each and every transaction. Next is I for isolation. It states concurrent transactions do not interfere. Last is D for durability. It changes, survive, crashes. These principles make transactional systems trustworthy, especially in banking, e-commerce, ticketing, and ERP systems. With that, let's dive into the 11th question, delete versus truncate versus drop. Now, these commands all do the same thing. They remove the data, but with crucial differences. Delete is row level removal, logged slower, can use where, and can be rolled back. Truncate does not use where clause and mostly it is irreversible. The third type is drop. It removes the entire table definition and data and it is completely irreversible. This distinction is extremely important for safe database operations and disaster recovery. Now let's move into the 12th question. So the 12th question is, what is a view? A view is a virtual table based on a query. Why views are used? It is used to hide complex joins, improve security, simplify repeated logic, provide abstraction layers. Views are heavily used to enterprise applications and BI too. Now with that, let's dive into the 13th question. What is a stored procedure? Stored procedure is a pre-compiled blocks of SQL that sits inside the database. Benefits: reusability, security, consistency, reduced network load, better performance, and many more. They allow complex business logic to run close with the data. Now we have the 14th question. What is the difference between char versus varchar? Character has fixed length storage. On the other hand, varchar has variable length storage. Char is ideal for country codes, gender, etc., which has mostly the fixed identifiers. Varchar is ideal for emails, names, addresses. Understanding this distinction leads to better storage optimization. Now, the last question in the theory section. What are window functions? Window functions allow you to perform calculations across rows while preserving individual records like group by, which collapses rows. Most common window functions are row number, rank, dense rank, lag, and lead, sum, over, average, over, and a lot more. Where they are used is your next question. We can use them in running totals, moving averages, trend analysis, time-based comparisons, leaderboards, cohort analysis, and a lot more. Modern SQL exams and interviews test window functions heavily because they reflect practical analytical skills. Now comes the next part of these interview questions where we will be dealing with practical query-based or scenario-based questions and answers. So now we are in the scenario-based or practical query-based interview questions and answers. So let's go through the questions and answers quickly because we will be creating a new table, entering the data. After that, run the queries. So let's go through the questions and answers quickly. So first we have the fetch the second highest salary from the employee data table and we have the answer here. It uses a subquery to exclude the highest salary and extract the next one. Now the second question is retrieve employees who have no department assigned. So this is the answer for it. It uses left join to identify unmatched rows. So what we are currently doing is we have a list of 10 interview questions and answers. So we'll quickly run the PowerPoint presentation and have a quick analysis on what we are going to face and how are we going to answer the question. And you can see the last line, right? This particular last line gives you a small hint of the logic we are going to implement. So once we are happy with all the overview of all the questions and answers, and then we will create new data tables. And inside the new data tables, we will add new data entries and then start question by question and run our queries and extract the outputs that we are looking to. Now, the Next question in the list is find duplicate email IDs in the table. And after that, we have display the top 3 highest paid employees. So here we have order plus limit, where we will limit the output to only 3 rows. And then we have count orders per customer. We will be using a count function here. Then get employees whose salary is above the department average. So first we will be calculating the average of salary, and then we will include that inside the subquery and find the employee who has salary greater than that particular value. Next, we have display employees hired in last 30 days. So this is related to our time date function. So we will use the current date and then subtract the interval of 30 days. Then we have get all customers who placed more than 5 orders. So we have to use group by and having functions here. Then retrieve the running total of all the sales, use a window function for cumulative logic. Then we have to remove the rows while keeping only the latest records. So it keeps only latest records per unique email. So we will be using unique function here. So this is the overall overview of all the 10 scenario based or demo based questions that we will be facing today. Now let's quickly jump onto the MySQL workbench and try to create the new tables, add the entries, and then run each and every single query for each and every questions that we have listed here. So now we are on the MySQL workbench. So this is the SQL training interview questions that we are facing. So let me also check the data table first real quick. So I have a doubt that I've already created a table on interview questions. So for better clarity, yeah, we have created a database, but there is no table inside this. But yeah, we do have tables. So let's open a new query prompt quickly and see, or we can use the same prompt. Let's check it. Use, let me expand, database interview. We are in interview and then show tables. Yeah, we do have created all the department employees order sales data. So let's quickly run the select commands star from departments. But if you are worrying about the queries to create the data sets, don't worry. So here you can see on my screen, we have the entire code documentation done for us, the SQL training documentation. So here you have the, commands for creating the table, inserting the table data, and then selecting the employees and all those things. And apart from that, if you scroll a little bit down, here are the places where we start with interview questions and their answers. This is the section. So this is the first question, right? So no worry, all the tables are created for saving time. And also this particular document is listed in the description box below. You can go through that and start running the queries along with me, right? So now let's go to the table here. Select star from department. So we have about 4 departments and the fifth one deliberately left as null because one of the questions was also listed as find the employees where a department is not assigned yet, right? Something like that. And we have a second select. Let's copy and paste quickly so that we save time. And instead of departments, we have employees. This is the employees table. And we have the employees here. Department is equals to null. So Frank is one of the employees where department is not assigned. So we will be extracting them in the runtime. And the third one was about orders. And we have the following orders along with the date time. And next table is sales. So we have the sales here, sales table. And lastly, users. Let's run. And there you go. So now we have a briefing on all the data table entries and the elements. Now let's go back to SQL file number 8. I think we do not need to create any tables so far. So I'll eliminate this particular part. And that brings us to the first question. Fetch the second highest salary from the employee table. Now we need to understand subqueries here. So we've already been through subqueries tutorial. So I have highlighted a small part of the single query which states select maximum salary column. So we have a salary column. Inside that, we need to find out the maximum value inside the salary column. So that becomes a subquery. And that particular subquery is encapsulated inside an outer query. So outer query is this one. So we need to select maximum of salary from employees where salary is less than the maximum salary of employees. So basically, it gives you a list of all the salaries which are less than the maximum salary, but we want the second highest one only. So for that, you can also add limit 1. If you don't add limit, what you will have is all the entire list of rows. But if we have limit, you'll just get one entry. So let's quickly run this. So we have this particular salary, which is second highest. You can also include employee name, right? So what was the name given for employees? So if we run the employee table here, we have name, right? So we can copy this field name, go back to file number 8, paste it here, comma. Okay. Right now, if you run this, you'll get the name of the employee. Okay. So what we need to do is employees dot name. This should resolve our problem. I think it's not working. Basically, this is how we run and we get the second highest salary. And there you go. Now, the second question is retrieve employees who have no department assigned. So here we need to perform join operations. So we are doing a join operation of left join on departments as well as employees table. And based on that, we will find a location where employee department ID is equals to null. And according to that, we will find out the employee's name. So let's run this query quickly. Left join departments D on employees department ID. So based on these IDs, we are finding or creating a join and then finding the employee. And there you go. So Frank with employee ID 6 and his salary is 60,000, but department is not entered, so it's on null. Now, proceeding ahead, we have the next question. Let me expand this. So the next question is find duplicate email IDs in a table. So here we will find a simple select query with email and count from users table, and we are grouping by email and we are grouping by having count star is greater than 1. So what this basically does is if one email ID, right, is counted for multiple times more than 1, then that particular email ID is been duplicated. So we need to execute this query here, and there you go. Alice at example.com is one particular email ID which has 2 entries there. It is repeated for 2 times. So we have a duplicate entry there. Now the next question is display top 3 highest paid employees. Remember the first query? It is completely similar to that one. So here what we are doing is we are ordering by salary and descending by salary, order by salary in descending order, and we are limiting to 3 entries. So we will have 3 entries. It is similar to the previous question. So quickly control enter. And we have 3 employee IDs, 2, 4, and 8. So these earn top highest salaries. Now next is count orders per customer. So we have customer ID and we are counting their order IDs as total orders from table orders, and we are grouping by customer ID. You can also do an order by thing here. So we can order by descending so that we can find out the highest orders. Let's try that. Well, let's execute this first and then try to plan out the order by query. So there you go. So we have customer ID and the total number of or total orders. Now let's get going with the next question. Get employees whose salary is above the department average. So we have already discussed this particular question. So what we are basically doing is we are encapsulating the query here. So let's format that. So here is our subquery. We are basically finding the average salary from employees where department ID is equals to this one. So we are finding the average salary and then we are comparing the salary with the average salary, and it should be greater than the average salary. Now let's execute this particular query, and there you go. So we have about 1, 2, 3, 4 employees who have salaries more than the average salary paid to overall employees. They must be in good roles. Now the next one is display employees hired in the last 30 days. So here we need to use the date and time function. Select star from employees. Interval is 30 days. I think interval is 30 is enough, or there must be a small query error here. So let's go to the next question. get all customers. So let us consider this particular query as your homework. You can let me know the answer for this particular question. Display employees hired in the last 30 days. Go ahead with the time date function and find out the answer for this. And please do let us know in the comment section below. Now, the next question is get all customers who placed more than 5 orders. So we are selecting customer IDs from orders table. We are grouping by order ID and having. So we are going with an aggregate function here. So we cannot use the other function, but having. So having is the only function that go with the aggregation functions. So enter, and we are having the details here. So I think nobody is having more than 5 orders. Let's go with another number, 2. So we have 2 customers, customer ID 1 and 2, which have more than 2 orders placed. That's the answer. And next one is retrieve running total of sales. So for extracting running totals, we need to have aggregates over date as running total from sales. Now let's run this query. And there you go. Now we have reached the last question of this particular session. Remove duplicates rows while keeping only the latest record. So what we are doing here is select maximum create this subquery and users U2, and we need to find out the unique email. And if that particular email is repeated twice, then we need to delete that, and we need to keep only the latest entry of that particular email. So we are also using a delete command here. Enter. So I think there are no duplicate emails entered, so we already removed them so far. So that's how you remove the duplicate entry so far. And with that, we have finished the top 25 most frequently asked theory-based interview questions and answers, as well as scenario-based or query-based interview questions and answers on SQL. Now, let's proceed with the important tips for SQL certification exams. Now that we have decoded the theory questions and walked into some most commonly asked interview patterns, it's time to shift gears and boost your exam performance. Interviews sharpen your fundamentals, but certifications validate them formally. Recruiters, hiring managers, and even senior architects look at certifications not just as badges, but as proof that you understand SQL at a systems level. So, in this section, I'm going to walk you through high value strategies and by top performing candidates. These are not generic tips, these are insights sharp by real exam patterns, real failure stories, and success paths. Now, the first one. Master SQL fundamentals deeply. Every SQL exam, whether it's Oracle, Microsoft SQL Server, PostgreSQL, or any cloud-based SQL assessment, it's fundamentally built on the same backbone. SQL fundamentals. The exam creators know that if you truly understand these foundations, you can handle any advanced question with confidence. Now, when I say fundamentals, I don't mean memorizing definitions. I mean truly understanding why and when something works. For example, joins are not just about combining tables. They test how well you understand relationships between entities. Subqueries check whether you can break down data problems into layered logic steps or not. A key skill in real analytics. Transactions ensure that you know how databases maintain consistency even under failures. Indexes test whether you understand performance, not just correctness. Certification exams love focusing on those areas because they expose whether you're simply writing SQL mechanically or whether you can actually reason with SQL. You'll notice that nearly 60 to 70% of exam questions revolve around these fundamentals, sometimes directly and sometimes hidden inside complex analytical questions. So before you jump into mock tests or dumps, invest time in mastering the foundations deeply. Once you have this clarity, the rest of the exam becomes significantly easier. The second one is practice SQL on actual exam engine. One of the biggest mistakes candidates make is preparing on generic platforms like SQL Zoo, HackerRank, LeetCode, or any online-based examples, but not practicing on the actual exam environment. Each certification vendor, whether Oracle, Microsoft, PostgreSQL, or even cloud vendors like Google BigQuery, it has its own flavor of SQL. That means the syntax, the built-in functions, the error patterns, and the way the system responds to your mistakes can all vary slightly. For example, SQL Server uses TOP for row limiting. Oracle uses row number or fetch first. PostgreSQL uses limit. These small changes or differences can completely change the behavior of a query. The advantage of practicing on the real exam engine is that it reduces the exam time surprises. You're already familiar with the UI, the formatting rules, the syntax behavior, and how strict the evaluator is. You also get comfortable writing queries without relying on the autocorrect, auto-format, or syntax highlight. This is exactly why top scorers insist on simulating the exam environment early. The more you replicate real conditions, the more confident and stable you will be under pressure. The third one is learn vendor-specific features. Now, let's talk about a very underrated area, vendor-specific functionality. Every SQL database implements the SQL standard slightly differently, and certification bodies intentionally test these unique features. Let's break down some examples. Oracle SQL, row number. It is used heavily for pagination and row limiting queries. NVL, Oracle's versioning of handle null values equivalent to is null or coalesce in other engines. If you don't know these features, you will misinterpret these questions and lose marks. For example, SQL Server uses top n function, a very common row limiting clause. The other one is try convert, a safe conversion function that avoids throwing errors when conversions fail. Again, Microsoft exams love to test these. Another example is PostgreSQL's JSON-B. PostgreSQL's powerful binary JSON format is heavily tested because it's a core strength. Rich window functions like PostgreSQL is known for analytical SQL, so expect questions on ranking, partitioning, and frame clauses. When you learn vendor-specific features, you're not just memorizing functions. You're understanding the identity of each database. This gives you an edge because you can decode what the question writer is expecting. The next one is fourth one, understand execution plans. Execution plans are game changers. Modern SQL certification exams are not satisfied with candidates who can simply produce the correct output. They want you to understand how efficiently the database retrieves that output. Execution plans reveal whether an index is being used, whether a full table scan is happening, how joins are processed, which query operations are most expensive. When you understand execution plans, you understand the internal mechanics of SQL engines. This helps you answer exam questions that revolve around cost optimization, indexing strategy, and query rewriting. For example, an exam may show two queries with the same logic, but ask you which performs faster. Without knowledge of execution plans, you are guessing. With understanding, you're simply decoding the behavior systematically. This is why high scores always study execution plans. It's a direct way to align your reasoning with how the database actually operates. Now, the fifth one, learn to interpret SQL errors. SQL certifications don't always give you perfect queries. Sometimes they intentionally include incorrect code and ask you to identify the issue. If you're not comfortable reading SQL error messages, you will struggle. Common exam patterns involve foreign key violations. These test your knowledge of referential integrity. Null violations is the next one. These test check constraints, default values, and null handling logic. The next one is type mismatch errors. These enforce you to understand data types rather than relying on generic casting. Even experienced candidates get stuck because they expect perfect queries. Remember, the exam is not just testing your ability to write SQL. It is testing your ability to debug SQL. Now we have the sixth tip, master join combinations. Joins are one of the most commonly or frequently tested topics in SQL certifications. But not just simple inner joins. The real complexity is in combinations and edge cases. You need to be comfortable with cross joins, self joins, and right outer joins, full outer joins, anti joins. Not exist right now, but in exams it may be there. Exams often place these joins in the context of tricky dataset structures, missing values, duplicate records, circular relationships, and asymmetric data. The goal is to test whether you can visualize table interactions mentally. When you master joins at this level, you can handle any data retrieval question under pressure. The seventh tip is focus heavily on window functions. Now, let's talk about one of the most important areas in modern SQL exams, window functions. These include row number function, rank function, dense rank function, lead function, and lag function, sum function, over function, average function, and a lot more. Partitioning and framing clauses are also important. Why are window functions heavily tested might be your next question. Because they represent analytical SQL, the core of modern data engineering, business intelligence, and analytics workloads. Window functions allow row by row analysis without collapsing the dataset. This means you can perform ranking, running totals, and trend analysis and change direction, all with elegant syntax. In certification exams, These questions are often look complex, but if you understand partitioning and ordering deeply, you can decode them instantly. So allocate special timing for mastering window functions. They are high marks, high value, and high impact. Now let's go with the eighth tip. The eighth tip is about use official learning paths plus practice tests. Another strong recommendation, stick to official learning paths. These are curated by same teams that design the certification exam. That means the content is aligned with the exam blueprint terminology and difficulty level. For example, Oracle University's learning path, Microsoft Learning modules for SQL Server, and Azure SQL, PostgreSQL official docs, and tutorial guides. These official resources also contain free practice tests. Use these to gauge your readiness. Consistent scoring above 85% is good indicator that you're ready to book the exam. Remember, random online sources like blog posts may be good for learning, but they rarely follow the exact same pattern. Trust official sources when preparing seriously. Now, the next tip. The next one is our ninth one, build at least 2 real-world mini projects. Certifications are not just theoretical. Practical experience massively boosts your retention and intuition. Building real-world mini projects help you develop muscle memory. Some ideas include a sales dashboard with aggregations and window functions, a user engagement analysis with session-level SQL, a logistics or inventory dataset involving joins, subqueries, and transactions. These projects strengthen your ability to handle multi-table analysis, a core exam requirement. The more you practice data challenges, the faster you'll decode certification exam questions. The 10th and the last tip, build a time management strategy. This one area many candidates underestimate. In SQL exams, the time pressure is real. Even if you know the answer, poor pacing can cost you the certification. Here's a simple but extremely effective strategy. Attempt all easy questions first. Mark medium questions for revisit. Leave complex analytic questions, multi-step queries, and optimization-based problems for the last 25 to 30 minutes. This ensures that you maximize your score early and avoid getting stuck. Remember, exams do not reward you for solving hard questions first. They reward strategic thinking. And with that, we conclude this model, a complete roadmap to succeeding in your SQL interviews and certification exam. In this session, you learn how to articulate SQL concepts with clarity, precision, and confidence. We've reviewed the most common interview question patterns, logic behind real-world SQL scenarios, and how certification bodies test both your fundamentals and your analytical mindset. The entire goal of this module was to help you think like a professional, not just write SQL queries mechanically, but develop a deeper reasoning style. And once you start thinking this way, SQL stops being just a query language. It becomes a tool for structured analysis, pattern recognition, and business decision making. With these fundamentals, you will walk into interviews and exams with not just knowledge, but confidence, speed, and strategic clarity. Now, take these insights, put them into practice, and start preparing for your next step in SQL journey. You've got this. As we come to the end of the SQL full course, take a moment to pause, not just to finish a course, but to recognize how much ground you've covered. When you first started, SQL may have felt like a new language filled with unfamiliar keywords, syntax rules, and database concepts. But now, SQL should feel less like a tool you're memorizing and more like a language you understand, a language that allows you to ask meaningful questions of data and receive precise, reliable answers. This course was designed with one clear objective, not just to teach you SQL commands, but help you think in SQL. Because in this real world, successful professionals are not those who remember every syntax keyword, but those who understand how data behaves, how databases are structured, and how to extract insights logically and efficiently. Over the last few hours, you didn't just learn SQL. You built a foundation that is used daily by data analysts, backend engineers, data engineers, business analysts, and even AI professionals across industries. From startups to Fortune 500 companies, SQL remains one of the most trusted and widely used skills in data ecosystem. Now let's take a structured walkthrough of everything you have learned and even more importantly, why it matters. So recap chapter by chapter learning journey. So the first chapter, Introduction to SQL and Database Basics. You began by understanding what SQL is and why it is still dominating in 2026 and beyond. You learned that SQL is not just a programming language, it's the standard way humans communicate with relational databases. You explored how SQL powers everyday systems, banking, e-commerce, flight bookings, healthcare, telecom, and analytics platforms. This chapter grounded SQL in reality, helping you see it's not just a theoretical concept, but as an invisible engine behind the modern digital systems. You also learn the difference between relational and non-relational databases, understanding when structure matters and when flexibility matters. This comparison laid the foundation for architectural decision making later in your career. Finally, you set up your own SQL environment, an often underestimated but critical step. By installing MySQL or PostgreSQL and running your first query, you crossed an important milestone from observer to practitioner. Now comes chapter 2, Basic SQL Queries. This chapter marks your transition into hands-on SQL. You learn how to retrieve data using select statement, filter it using where, sort it using order by, and control result size using limit and distinct. These are not beginner concepts. They are most frequently used SQL commands in production systems. You also learn how aggregation functions like count, sum, average, minimum, and maximum help transform raw data into meaningful metrics. This is where SQL starts becoming analytical, where you stop looking at individual rows and start identifying patterns. By end of this chapter, you had the core skills required to answer real business questions using data. Now we dive into chapter 3, understanding data types and operators. In this chapter, you learn something many learners overlook. Data types matter. You explore numeric, string, date, and Boolean data types and how choosing the right data type impacts storage, performance, and accuracy. You also learned how arithmetic and logical operators allow SQL to perform calculations and comparisons. Operators like between, in, and like taught you how to filter data intelligently, skills that directly translate to writing clean, efficient queries in real systems. This chapter helped you move from writing queries that work to writing queries that work correctly. With that, let's make a transition to chapter number 4, inserting, updating, and deleting data. Here's where you learn SQL isn't just about reading data, it is also about responsibly modifying it. You practice insert, update, and delete operations while understanding why careless data manipulation can cause serious issue in production environments. You learn safe deletion practices, conditional updates, and the importance of verifying data before making any changes. This chapter introduces you to the mindset of a professional, someone who understands that data integrity is as important as data access. Now comes chapter number 5, mastering SQL joins. This is where SQL truly starts to show its power. You learn why joins matter and how real world data is almost never stored in a single table. Through inner join, left join, right join, and full outer join, you learn how to combine data meaningfully across many tables. You practice multi-table joins and saw how business insights emerge when data relationships are used correctly. This chapter is often a turning point where learners realize SQL is not just about tables, but also it's about relationships. If you understand joins well, you already stand ahead of many beginners. Now comes chapter 6, grouping and aggregating data. This chapter focuses on summarization and insight generation. You learn how group by transforms detailed records into aggregated summaries and how having allows you to filter aggregated results. This distinction, where versus having, is subtle but very crucial. Here, SQL starts behaving like an analytical engine. You move from row level data to trend level thinking, which is exactly how data is used in dashboards, reports, and decision making systems. Now comes chapter number 7, which is about subqueries and nested queries. In this chapter, you learned how to write queries inside queries. Subqueries taught you how to break complex problems into smaller, logical steps, just like solving real world analytical problems. You explored single row, multi row, and correlated subqueries and saw how they can be used in select, from, and where clauses. This chapter sharpened your problem solving skills and introduced a more modular, logical way of thinking in SQL. And now comes chapter number 8, which is about data modeling and relationships. Here, you step back from writing queries and looked at how databases are designed. You learned the difference between primary keys and foreign keys. You explored one-to-one, one-to-many, and many-to-many relationships and understood why normalization exists. This chapter helps you communicate better with data architects, backend engineers, and system designers. It also explains why well-designed databases make SQL queries simpler and faster. And with that, we come to chapter number 9, indexing and performance tuning. In this chapter, you learn that performance is not accidental, it is designed. You explored how indexes work, when to use them, and how they speed up query execution. You also learned basic optimization principles that help queries scale with large datasets. This knowledge separates casual SQL users from professionals who work with real production systems. Now we make a transition to chapter number 10, which is about views, functions, and stored procedures. This chapter introduces you to reusability and abstraction in SQL. You learn how views simplify complex queries and functions encapsulate logic, and how store procedures allow SQL to behave more like a programming environment. These concepts are widely used in enterprise systems and play a major role in reporting, automation, and backend workflows. Now comes chapter number 11, transactions and error handling. Here, you learn how SQL ensures reliability and consistency. You explored begin, commit, and rollback and understood the importance of asset properties. This chapter showed you how databases protect data even when systems fail. This knowledge is critical for finance systems, inventory systems, and any application where data accuracy is non negotiable. Now, chapter number 12, real world SQL projects. This was where theory met practice. You applied everything you learned by building a mini e commerce database, writing sales reports, and analyzing customer behavior. These projects mirror real world workplace tasks and help bridge the gap between learning and doing. Now, the chapter 13, SQL for data analysis. Here, SQL became a true analytical tool. You learn case statements and window functions like rank, row number, lag, and leak. These are powerful features and are used in advanced reporting and analytics platforms. This chapter aligns SQL with modern data analytics rules. Now comes chapter number 14, integrating SQL with Python. You learn how SQL fits into large ecosystems. By connecting SQL with Python and Pandas, you saw how data flows from databases into analytical and machine learning workflows. This integration is essential for data scientists and engineers. Now, with that, we come into chapter number 15, which is SQL interview and certification preparation. You will learn how SQL is evaluated in interviews and certifications. You explored common interview questions, best practice answers, and how to demonstrate SQL knowledge practically. This chapter prepares you not just to know SQL, but to prove it. Now let's go through a roadmap which explains you what to learn next. Now that you have a strong SQL foundation, here's what you can go with next. Advanced query optimization and execution plans, advanced window functions and analytical SQL, database internals and indexing strategies, SQL for big data platforms like Snowflake, BigQuery, and Redshift, SQL in real-time analytics systems, SQL for data engineering pipelines, SQL certifications from Oracle, Microsoft, and cloud platforms. Think of SQL not as a destination, but as a core skill that grows with you. SQL is one of the rare skills that ages well. Technologies change, tools evolve, but SQL remains relevant because data remains relevant. Every decision, every product, every AI model begins with data, and SQL is how we access it. If you have completed this course sincerely, you are no longer a beginner. You have the confidence to explore data, ask questions, and solve problems. The real learning begins now when you apply SQL daily, break queries, fix them, optimize them, and use them to create value. Thank you for committing your time and effort to this journey. Keep practicing, keep questioning, keep building. And remember, those who control data shape decisions, and SQL gives you that control.
Let's get started with logical functions in Excel. So before that, this will be our dataset. So you can see on my screen. So this is flight related dataset, and we have customer details, airport details, and also some capacity and cost per all the revenue related details here. So we will be using this particular dataset. to work on Power Pivots, Power Query, data cleaning, and dashboards, pivot charts, and all of those. But now let's get started with the easy part. So here we have the logical functions in Excel. So the day-to-day logical functions that you will be using in Excel will be the if condition. In case if you have multiple conditions, then you can go with nested ifs, or also called as multiple ifs condition in simple language. And apart from that, if you are a fan of using switch condition in place of multiple if conditions, then you can also go with switch. And here you have the and operator and or operator here. So we have a sample data set. So this is student related data set. So here you can see we have some student IDs and their respective marks. So we have a wide combination of marks here. So let's say 91, 32. So let's keep the minimum count as 35 for passing marks. So based on that, we can also predict some results here. So here you can see I've already done some tests. So using the if condition, if the marks is greater than 35, then pass or fail. So based on that, you can also implement the same. So let's quickly try to implement that. So to implement the if condition, all you need to do is just type down if and press tab to select the function and the logical test. So this would be my logical test. So the contents in cell B2 should be greater than 35. If it is greater than 35, then it should be giving me a value as pass. Else, you can take it as enter, and there you go. Now you can just quickly drag and drop and then start. So this particular function where I just clicked, right, let me just quickly undo that. So here you can see if I expand my spreadsheet, so here you can see a small box, right? When you just click on that box, you get the highlight option, which is nothing but the flash fill. You just double click that, it will extend this particular formula to the entire column. That's the one. There you go. Now you might be wondering, this is just simple. Why just go with an if function for that? You can just check the marks and just add that, right? But we have a very small data set, probably about 20 rows. But in case if you have 200 rows, or if you have 2000 rows, and it becomes a mundane task of every day, right? If you are in business analytics, then you might have a brief idea of what I'm speaking. The values might change every day, and you might have to be on the spot with all the records, right? And you need to be accurate for that as well. And you cannot spend time manually checking each and every record. So in that situation, these kind of conditional statements come handy. Now, let's say I want to go with multiple conditions. Let's say like we have taken a wide variety of marks here, 33, 35, 91, 59, 45, and I want to categorize. So in business analytics and data analytics, categories are the ones which play a major role, right? So in the same way, let's consider this small and simple data set for understanding how you can categorize using the if conditions in Excel. So that is called as a nested if condition or multiple if conditions in a regular routine language. So in the same way, so here I have done it already. So if I highlight the cell, you can see the formula. So it is completely similar to the if condition, but the only difference is we are separating them by a comma, right? So let's get started. So it is similar to if. This is the one ifs, and the logical test will also be the same. Should be greater than 85. In that scenario, give me the value as distinction. Now the next condition. So I'm separating them using a comma. Now again, the logical test, if cell B2 is greater than 65, then give me first class. Now the third condition, separated by comma, if it is greater than 35, then give me pass. And the last one, if this particular cell is less than 35, then give me the candidate has failed the exam. You can close the bracket and done. Now again, you can simply employ flash fill to get the records for you. Now we have switch. Now there is not much difference between nested ifs or multiple if conditions and a switch. The only difference is you need to start the switch case with a condition which is true. You need to have that condition, and rest everything is same. Now I can just quickly copy and paste this function here and replace the ifs with switch. And the difference I was talking about is nothing but a true evaluation. And there you go. Now you can also employ the flash fill once again, and you have the results here. Now we have the logical conditions, which are and or. So again, let's say I wanted to find out some conditions. If the candidate is having certain marks, right? So if the candidate, let's say I want to filter only the first class candidates or the past candidates. So I want a condition. If the values are greater than 85 and 90, then I want those distinction candidates alone. So I can do that. So what you need to do is just go ahead with the and condition equals to, and there you go. And the logical function is the cell B2 should be greater than 85 and cell B2 should be less than or equal to 100. If this is true, then I have the candidates who are having marks greater than 85, only the distinction candidates. Similarly, let's say I wanted to find that only the candidates who are having first class or maybe distinction. You can also implement the same using an OR condition as well. So these simple examples are given to understand the functionality of how these logical functions work in real time. Now you can also go with the same is greater than 85 and B2 is less than or equals to 100. There you go. So this is how you can employ simple logical functions in Excel. I can also go ahead with adding the indentation, no rows format, repeat. Now you can also go ahead and add those formattings like all the boxes and all those things, which are pretty basic. Now with understanding these basic logical functions in Excel, we can quickly now move ahead into the lookup functions in Excel. Now here you can see we have some customer data and first name, last name, email ID, age, gender, and PIN code. Now this is the part of the flights data that we originally have for our dashboard. So here we are going to understand how lookup functions basically function in Excel. Why are they even used, right? Let's say we have about, I think we have about 10,000 entries here. Let's quickly find that. So there you go. You can select any cell and hit Control Shift and lower arrow key to count the total number of rows. So we have 10,000 rows. Now here I have a couple of customers and their IDs. And now I wanted to find out their PIN code, right? Or some details related to the phone number or email address. Now I can't go ahead and manually find out each and every one of the rows and then recognize if this ID matches with that particular ID in the given table and then extract the PIN code, right? This could be time consuming. And in real world scenarios, this is not at all accepted. So to save time and increase productivity and be accurate with your results, we have a couple of lookup functions in Excel. So you can also go ahead with the index match and everything, but to minimize complexity, lookup would be the best one. So in Excel, we basically had two types of lookups initially, the VLOOKUP and HLOOKUP. So V stands for vertical lookup and H stands for horizontal lookup, and then came the advanced version, which is XLOOKUP. To be honest, if you learn about XLOOKUP, that would be all for you. But to know the fundamentals and just to be on the safer side, when you are facing an interview and someone asks you how VLOOKUP and HLOOKUP works, then you should be prepared, right? Unless you understand how a VLOOKUP and HLOOKUP works, you cannot directly proceed with XLOOKUP. So let's get started with VLOOKUP. Now, I wanted to find out the PIN code for this particular customer ID. Now, how did I do that? So here, if I highlight the formula, here you have a VLOOKUP function, right? So the first I2 value is the lookup value. You need to make sure that Excel understands which value are you fetching for, right? So we want to address the person. This is the person, and I want to find out the details related to this particular person. So that person is this particular cell in this scenario, which is cell I2. And now, where can I find the address book of this person, right? So give me the address book, right? The address books you have, where I can just fetch all the rows and entries, right? And then find out the matching row and give you the data. So where is this phone book? So this particular table is your phone book. And then you will also explain VLOOKUP in which page, or let's say in the terms of the phone book, in which page can I get the details? Can you give me the rough idea? So here I have the pin code in the 7th column. So in this scenario, this can be considered as the page number in the phone book. So what you're basically doing is you're giving the name of the person and the address book and in which page to find the details for. And you are also giving the 4th parameter, which says I want the exact match. Let's say we consider a name called Jack. The Jack person might have a second name as well. There could be possibility that in your phone book you might be having 3 to 4 Jacks with different second names, or maybe Jack doesn't have a second name. Now Excel would be confused. Out of the 4 to 5 Jacks, which Jack should I go ahead with? In that scenario, it might give you the near match situation and can give you the multiple values, but you are supposed to explain Excel that I want the exact match. So here you have C1568A, right? A lot of numbers and a combination of alphanumeric ID. So if it finds similarity between the alphanumeric values, it might yield multiple outputs. You don't want that to be happening, right? So you want to provide an exact match so that it understands I need to provide the user with the exact details. So that's how it works. Now that we have a brief understanding, I know it's a little fast, but again, let's go through a demonstration so that you understand it in a much better way. So to address this, let's type down VLOOKUP. So this is the function. Now remember, the first part was the name of the person, right? So here is my name, or in terms of the function, you can consider this as lookup value, right? Now comes the address book, which is table array in terms of VLOOKUP. Now this is my address book. What I'll do is select all the columns here. So I have selected all the columns, and this particular address book has 7 pages. In the terms of Excel, we have 7 columns. Now you need to specify Excel that where to look for the value. So I want to specify column number 7. I'm telling Excel that you will find the pin code of this particular customer ID in the column number 7. Now this is the column number 7, which has the pin code details. Now the last parameter, which is approximate match or exact match. You're specifying here. If I find multiple similar entries, can I give you multiple outputs? No, I don't want approximate matches. I want the exact match. So for that condition, you might have to give the false, or you can select false from here as well, or you can also state 0, and it will be self-understood. And you have the pin code here. Now what you can do is quickly drag and drop or flash fill so that you find the IDs or pin codes for all the IDs specified here. Now let's come back to HLOOKUP. The only difference between HLOOKUP and VLOOKUP is the data will be horizontally set in HLOOKUP and vertically set in VLOOKUP. Now before we move into HLOOKUP or any other further lookups, we need to understand one thing. The lookup functions, both vertical and horizontal, work from left to right, and in HLOOKUP, top to bottom, right? What is left to right? Now we had our customer ID here in the leftmost section and the output or the pin code in the rightmost section. Now VLOOKUP will function from left to right. When the output or the expected output is in the right section, the VLOOKUP will give you the answer. But in case, let's say we had our customer ID in column B and pin code in column A, then it would be right to left. In this scenario, VLOOKUP could not give you the answer. That's the problem. So whenever you're working with VLOOKUP, make sure that you are output or the expected output is in the right section and your lookup value is in the left section. So remember, VLOOKUP works from left to right. And similarly in HLOOKUP, it works top to bottom. So this also can cause a constraint, a limitation. That's the reason why we came up with XLOOKUP. So we will understand XLOOKUP further. Now let's deal with HLOOKUP first. Now we came into HLOOKUP. Let's keep the scenario same so that it is easier for you to understand. So the case is same. So we have the customer ID. So here the first row. Now we are dealing with row-wise entries. Now the first row is about the customer details. And again, we have about 10,000 columns here. We had 10,000 rows in the first place. Now we have 10,000 columns. That's the difference. And now let's go back. So here I want to find out PIN code for the given customer ID. Now how would I design the HLOOKUP function here? So here we have the sample function. So in the same way, we are giving the name of the customer or the name of the person, which is the lookup value. Then the phone book, which is this particular 10,000 columns of data. And then the row number, which page, right? Previously we had the column number, but here we will have the row number. That's the only difference. And we will be specifying the row number as 7. Previously, we had the column number 7. Here the page number is 7, but instead of column, we are specifying rows. And again, the last parameter will be exact match, which can be false or manually can type down as 0. Now let's try to implement this. So here, we will type down HLOOKUP, tap to select, and now the name of the person or the lookup value in terms of Excel. So the lookup value will be this one, comma, the phone book or the table array. So I'll just select this. So we will be using Control Shift arrow key and again Control Shift arrow key. So the entire table or the address has been selected, comma. Now I want to specify the page number or row index number. In terms of VLOOKUP, we had column index number, but in terms of HLOOKUP, we will have row index number, basically the page number. So here I will specify the page number as 7, and the last parameter, do you want to proceed with approximate match or exact match? By default, remember this, anytime you're dealing with lookups, never choose approximate match. Go ahead with exact match. Of course, there will be scenarios where you might have to go with approximate match, but those are very rare situations. Most of the times you go with the false one or the exact match one, right? So I will manually type down 0, or you can also choose the arrow keys and then press tab to select the false, then close the brackets, enter. Now you have the PIN code, right? The same, flash fill, and then you have all the details here, or you can just extract this. Do you want to replace it? Okay. You can also type down again. Okay, so cell address. So here you can provide the complete, or you can, freeze these cell addresses so that you get the exact match. So that's not a big problem. So basically that's how the HLOOKUP works. And now let's come into the XLOOKUP, right? So now remember the previous time when we worked on VLOOKUP, where we understood VLOOKUP only works in left to right scenario, but not from right to left. And again, we also had to select the entire table, right? We had to provide the entire phone book, right? But in terms of XLOOKUP, you don't have to provide the entire phone book. You can just provide the page number and it will give you the result. Now, let's look how XLOOKUP works. Now it's simple. XLOOKUP and the lookup value, which is the name of the person or the customer ID, and lookup array. So this particular data will be in the phone book's first page, which is this particular array, comma, and where would be the PIN code, which will be in the page number 7, so or the column number 7, and ultimately you are providing that particular written array. And lastly, you're also providing that I want exact match, or if not found, what should I do, right? I think this is more than enough for XLOOKUP, and you have the details here. You don't have to specify exact match, or you don't have to specify approximate match, and it also gives you the freedom or the liberty to customize your output. In case if some values are missing, Then you can also type down some text notification saying the value doesn't exist or you need to update your records or something like that, right? It is more advanced than VLOOKUP and HLOOKUP combined. Now you can also drag and drop this particular formula and we have all the pin codes here. Now this is how the lookup functions in Excel work. Now that we have a detailed understanding on lookups, we can now switch directly into the dynamic arrays, right? So there are a lot of dynamic arrays present in Excel, but the most often asked in interviews and most frequently used in day-to-day tasks are these ones: the filter function, the unique function, the sort function, the sequence, and random arrays. Now you might be wondering, why do we have to understand filter and sort and unique, right? Those are basically inbuilt here. If I just go to the home menu, home ribbon, and then go to the editing group, you can directly see the filter and sort options working here, right? You can just select the sort function and then A to Z, which is the lowest to highest, and Z to A, which is the descending order. It can be done, right? Why to proceed with an actual formula when I have a built-in tool? Again, when you are attending an interview, then the interviewer wants to understand your caliber in Excel. How good are you with Excel? How good are you with the basics of Excel, and how do you understand the functionality of Excel? So that is where you need to understand the implementation of these functions like filter, sort, and all those things. Now, which is really simple here, we have again created a small data set. So we have a small employee data set. So we have name, gender, department, age, date joined, salary, rating, and manager. So here I've already implemented a small filter function where I wanted to find out the team details of the manager, Raj Malhotra. So Raj Malhotra happens to be the manager of a couple of people in the entire company. So I want to find out the details of all his team members. So for that, I would like to proceed with a filter function. So whenever you click on this particular table, you can see the entire table is highlighted, and you have also a shadow kind of a feature, right? So you can select any of these cells and it will not affect anything, but the actual filter function is in cell L2. This is where your filter function is written, right? So what I've done is I have selected the entire data table, which is starting from here to this part, and then I have provided the column I, which is related to the manager, and I'm filtering out manager with specified name, which is Raj Malhotra. You can see the text function here. Let me increase the cell size, or I can do it again here so that you can have a better understanding, right? So let's copy the filter function and place it somewhere here. And now, instead of Raj Malhotra, let's say I want to find out the details related to Sunita Rao. So let's write down equals to filter and array. So this will be my entire array, Control Shift arrow keys, comma. And now I want to provide this particular array, comma, or should not be comma, which should be equals to double quotes, Sunita Rao, enter. So here I have the details related to Sunita Rao and her team. So we have about 4 members in Sunita Rao's team, and she works on both operations and marketing. And these are the details, the salary, and all those details. Great. Similarly, we have unique. Now, unique is something which is self-explanatory. It's like the name speaks for itself. It's like the unique entries in this particular team. So again, let's understand how unique works, right? So let me copy and paste this here. And then let's say we have a query where we want to find out the unique categories or unique products in the entire sales related data. In this case, I want to find out the unique teams present in this company, right? So what I can do is provide equals to and then unique function. And then I want to find out this particular department. Control Shift, lower arrow key, and there you go. So we have a spell error. Yeah, I think this particular function is working here. So not a problem. Let's copy and paste this somewhere here, and then equals to unique, then There you go. Now you have the entire departments list here, and these are the unique departments we have, right? And proceeding further, we have the sort function. Now again, sort function is helpful for all the situations. If you wanted to sort the names based on characters, if you wanted to sort the data based on salaries, date joined, or anything, you can just simply go ahead with sort function here. But in detail in interviews, if the interviewer is asking you to explain the functionality of sort via a formula or manually, then this would come handy. So here, let's say I want to use the same data table, and now here we have salary details, right? Starting from Kavya Gupta and all the other details here, right? Now I want to sort this entire table based on salary in descending order. So how would I do that? It is as simple as it sounds. It might look complicated, but it is simple. Now let's say I go to the formula and here I highlight it. So here you might see sort B to 1 or I-27, which are the cell addresses, and then 6 from a -1. It could look complex, but it is not. So let me dilute that for you. So I'll copy this and paste it somewhere here so that we don't face any spell errors. And then equals to sort. This is the function we want to select. Now here, in terms of Excel language, it wants to know where is the array. So my array is somewhere here. So I want to select this particular array. There you go. This is my array. And now we have about 1, 2, 3, 4, 5, 6, 7, and 8 columns. Now I want to go ahead with salary. So the salary column is number 6. So that is what the number 6 stands in the formula. And now sort order. We want it in descending order. So we will provide -1, press tab to select and enter. So there you go. Your data set is all ready. So now we have the highest salaried employee in the first place and the lowest salaried employee in the last place. And now you have successfully sorted your data. Now, sequence is something which comes handy on everyday tasks. Let's say you wanted to write 100 numbers, or you wanted to create a data table where you had about 100 students and you wanted to provide unique roll number or ID to the students, then this comes handy. You cannot just type 1, 2, 3, 4, 5, 6, right? If you just write a formula where you wanted to input 100 numbers, it just does it, right? So let me show that for you. I have simply provided sequence of 10. It gave me 1, 2, 3, 4, 5, 6, and 10. So let's do that once again so that you understand how it basically works in real time. So here I want to sequence 10 numbers. So all I do is sequence and provide the number of entries you want. There you go. As simple as that. Now let's say you wanted a matrix. That is also possible. What you can do is provide sequence and then number of rows. Let's say I want 5 rows and 3 columns, just like the one we created here, and enter, and there you have random numbers in sequence. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13, 14, 15. These are in series. Speaking of random, you have another function for that, which is rand array, random array. Now, whenever you implement random array function, it gives you the values in decimals. But in case if you want it in integers, you can specify that particular input. So let's try that once. So here I want to create random array and I want about 10 rows. Enter. It gives you in decimal values. But now I want it to provide me in integers. For that, you can provide this equals to random array, and I want 10. I can leave the columns blank, and I can leave the minimum value as, let's say my minimum value should be starting from 10 and the maximum value should go up until 20, and then I want it in integer format, so I will select true, enter. So now I have these values here, the random entries, starting from minimum number to the maximum number and in integer format. So that's how random array works. So far so good. We have explored the dynamic array functions, which are here: filter, unique, sort, sequence, and random arrays. Now we can proceed into data validation in Excel. And again, data validation is also simple, but also very crucial when it comes to day-to-day functions in Excel. Now we will also consider the same data set that we worked on previously, which is the employees data set. Now we have about 25 entries here. But in case if you had about 250 entries or something more than that, and you had to manually add all the employee details, like let's say department details or the gender details, right? Or the manager details. So let's go back to dynamic arrays, and here we have department related data. I'll just copy this and paste this somewhere here. I don't want unique there, and I want a couple of names here. Or we can just simply employ our unique function here, and this is the array. Enter, and we have our managers. Let me quickly copy and paste it somewhere here, and we don't want these anymore. And this will be deemed as manager. I think that should be good enough. Or you can also go with gender, male, female, others. Right? Now, let's say I wanted to enter these details here in terms of a drop-down menu. So in that scenario, what I do is go into data, and here we have data validation tools. Go into data validation, and here you have a wide variety of options. You can go with any value, whole number, decimal, list, date, time, text length, custom. But now I have a list ready, so I'll go with the list. And now where is the source? So my source for gender is somewhere here. Now you can also provide this as the source, or you can choose to manually write them down as well. Now apart from this, you can go with an input message. Select gender. Please select from the drop down only. And now error, wrong entry. Only the drop down values. So this is a few conditioning you can make, and then your data validation or drop down menu is ready for you. Now you can quickly drag and drop this, and your data validation is ready. So whenever you select any of the cell, you will be provided with a message. Select gender. Please select from the drop down menu only, and you can select any of the details. There you go. And let's say instead of the provided details, I try to manually enter some mistake. Then it will give me an error. Only the drop down values are allowed. Cancel, and now I can go with the original selection. Let's say for this one, I want to go with male. There you go. In the same way, you can also proceed with department. Now you can select any cell here, go with the data validation, and then go with the settings. And here I want to go ahead with list, and my source is somewhere here. Then okay, you can drag and drop, and you have the values. And similarly, the manager one as well. Go to data validation, list, and then the source is right here. Done. Now you can easily enter the values you want in a perfect way without any errors. And the department would be IT, and the manager would be Raj Malhotra. So this is how data validation in Excel works, and there are a lot of other options as well. If you wanted to explore more about data validation, I will link the data validation complete tutorial in the description box below. Now with that, we can continue with conditional formatting. Now for conditional formatting. So before we understand conditional formatting, let's say again, we have a task to identify students who have failed in the exam and who have passed in the exam. And here we have about 10 students, which shouldn't be a big trouble. But in case if you had about a lot of other values, maybe 10,000, if you consider a business scenario, and if you have to find out the volume to traffic, traffic to leads, leads to orders, and orders to revenue details, and you have a funnel analysis, then in that scenario, you want to quickly save time and highlight the values which are underperforming, right? In those scenarios, if only you had a tool which can directly point you to the position which product is underperforming and which product is meeting the KRA standards or KPI standards or the targets that you kept, right? That would be wonderful. So in the same way, we can consider the small 10 student dataset which has their student related marks details and their totals and everything. And you can identify which students have failed and which students have passed. So the implementation of conditional formatting is really simple. You can just highlight the data where you wanted to implement conditional formatting, then go to the home section, and here you have conditional formatting. And again, conditional formatting isn't just about highlighting the failed candidates and the past candidates. You can also create some result bars, right? Based on the progress bar, based on the marks, you can also create progress bar. Here you have the gradient fill, solid fill, and top to bottom rules. You can also segregate the data, top 10%, bottom 10%, above average, below average. Apart from that, you have color scales, and you can also add some manual rules or customized rules for your conditional formatting. It's not just about comparing the number higher than 35, lower than 35, then provide detailed result on that. It's not like that. If you wanted to implement a customized formula, let's say you wanted to find out your target, right? Let's say you wanted to have a target of 50,000 sales in a provided time period within 1 month or within the first quarter, then you can customize your formula and then input that. And based on the custom formula, you can also get the results done with conditional formatting. And I will link that tutorial in the description box below. And for now, let's understand the basic functionality of conditional formatting. So I want to highlight the cells with less than 35 marks. And then there you go. Now, that's how we identify the students who have failed in one glance. Now, we will dive into what-if analysis, which is another most frequently used function in Excel in terms of business analytics and data analytics. Now, I have two sample datasets here. So the first one is the sales data. So here we have a couple of products, A, B, C, D, and E. The quantity sold, the price on which we have sold them per unit, and then the total amount which we have earned, and the total revenue which we have generated, and which is the expected revenue. Let's say we crossed, we had a target. Let's imagine we have a target of 1 month, and we have crossed 20 days, and we have 10 days remaining. And now we have reached about 38,000, and our expected revenue is 45,000. Now, what we could do in this 10 months? Now, how many number of quantity of this particular product, which is E, should be sold to reach this particular target? Now, how do you count that? Now, this might look simple because we have a very small data set here, but in case if you're having a bigger data set, then the values could mismatch sometimes. To be on the safe side, to be perfect, you can go with what-if analysis. Now, we can start with what-if analysis. For that, you can go to data, and here you have what-if analysis, and here you have goal seek. For this particular implementation, we can go ahead with goal seek. Now, goal seek wants to understand the set cell. This is the cell which I want to set. To which value? I want to set this cell to the value 45,000, which is my expected revenue number. And which cell you want to change? I want to, focus more on product D or product E because these are the underperforming products. Let's go with product D because it is the least number. I want to focus on this product, and I want to find out how many number of product Ds should I sell in order to reach this particular, the goal of 45,000 or the target of 45,000. So set value, which is total revenue, D7. This is the one which I want to set. and to which value you want to set that. I want to reach or set that value from 38,000 to 45,000, which is my target revenue. And which cell you want to change, which cell you want to check how many number of products you need to, what is the permutation combination here? That's the cell you want to select, right? So I want to change this cell, which is B5, and then check how many number of products that I need to sell so that I reach my target. So you can just quickly select OK, and then it has run some formulations for you. And now you need to sell 45, right? So 45 or 46 minus, let's select OK. So equals to 46 minus 21 is 25, right? So you need to sell about 25 more of these products in order to reach your target. So basically it tells you need to sell about 46 numbers. If you had sold 46 of these products, you might have reached your target. So that's the expectation here, and that's how you find out your performance here. Now similarly, let's go ahead with another example here. So here you have a future fund amount, and here this is your EMI, which is the amount you are depositing to your funds, and then you have 25 years of tenure and your returns are 10%. So this is the amount you will be refunded after this particular tenure. Now let's say I wanted to know if the returns percentage is below 10% or if it goes above 10%, then what could be my changes in future fund amount, right? So if I want to find out that, it's really simple. Now you need to go and assign this cell with the location of this particular cell, which is your actual number, which you currently have with this particular detail. 10% of return, tenure is 25, and EMI is 12,000. So enter. Now you can drag and drop this to the last section with all the permutations and combinations, starting from 7% to, okay, I should have gone with this. Okay, not a problem. And now you should select all these cells. Let me quickly erase that. So my value was somewhere here. So I need to change these or cut these and paste it here, and this one here. I can quickly remove these cells, shift up, and there you go. Now when I had 10%, this was my returns. So I'm giving the address location, and then I want to drag and drop this to the last cell. And now I want to select the entire data array and then go ahead with what if analysis. And here I want to select the data table. Now I want to find out if my cells vary with this percentage, right? So this is the percentage cell, right? So I want to provide this and enter. Now I will have all my values. In case if the returns percentage was 10.5, this would be the amount I would receive. Similarly, if the returns percentage was 14, this would be my amount. If the returns percentage reduced to 7%, this would be my amount, and all the way ranging from 7 to 9.5, these would be my returns. So this is how the what if analysis data table function works. Now with these discussed, now we have a strong foundation of the basics of advanced Excel. Now relies the best part, or the most critical and important part, understanding pivot tables, pivot charts, Power Query, and data visualization, creating dashboards and reports. Now with these strong foundations or the basics on advanced Excel, now we can proceed with the advanced versions or the critical and tough versions, which are about understanding pivot charts, pivot tables, Power Query, data cleaning, data visualization, creating charts and graphs, completely functional and interactive dashboard in Excel using slices and all those functions. Now that said, let's continue. So now we have reached to the next section where we will learn the pivot tables, pivot charts, dashboards, etc. Now, let me open up a quick dataset for you. So we have 5 different datasets. So before we enter into the actual dataset, let me explain you one thing. So here we have 5 years of dataset. So the years start from 2022, 23, 24, 25, and 26. Now, why 5 different datasets? So in reality, when you're dealing with business analytics or data analytics in the industry level, the basic expectation is to have data sets separated by dates. So in this case, you might be considering week-on-week analysis, day-to-day analysis, month-on-month, year-on-year, right? So to replicate a similar scenario, I am taking 5 different data sets and the period will be a little bit bigger so that you can decrease the level of complexity. So these are the 5 years data sets and we will be using one automation for that so that it will be easier for you to work on the data sets or dashboards in future. So I have created a small copy of one of these data sets. It is not mandatory here. So I have created this just to understand the data cleaning purposes only. Later, the rest of these data sets will be implemented to create a dashboard or pivot charts and everything via Power Query. That will be a next lesson. For now, let's go back to the sample copy that we have created. So this is the copy data set, just so that we understand the basic data cleaning, removing empty cells or separating the first name, customer ID and everything. And if you wanted to include any of the custom calculations. So the basic day-to-day ones, which are simple and easy to understand. So let's get started. So here we have the date dataset firstly, and region, city, airport code, and here we have the customer details. So if you look at the customer details, you can see we have cust 0001 Jennifer Smith. So obviously this would not be the case when you are actually working with the data. This is not the basic expectation. You might be looking for something like customer ID, CUST001, and then customer first name Jennifer and customer last name Smith, right? So this is your basic expectation. And coming into email address, so are there any inconsistencies? So far so good, no inconsistencies here. And coming into mobile number, we have country code and rest of the other numbers as well. So it might not look like it's a big trouble here, but when you are working on the dataset, when you are importing the data to any of the BI tools, or maybe if you're importing the data via Power Query, then what Power Query does, or Power BI or Tableau, they kind of self-imagine. Sometimes they have their mind of their own and they consider these symbols. So here we have +1, the country code for America, and then separated by hyphens. So they might consider these symbols as mathematical symbols, and they end up creating mathematical calculations, and then we will have a final number, which is 850 minus 605 minus 5432 plus 1. It might yield a logical or numerical value, which is what we don't want. So here we might have to create some data cleaning here. What we'll do is we'll just eliminate the +1 and then hyphens, and we'll just have the actual phone number here. And then here we have the age numbers. So we have 32, 33, 58, 12, 1, a lot of them. But in case if you're working on data analytics, then you might want to consider something. Whenever you're booking tickets, whenever you're reserving tickets, there will be a separate column which says, is the candidate or is the passenger senior citizen? Is the passenger children or not, right? So to understand that particular variant, we might have to create separate sections of data. So I mean separate groups, right? So age group of 1 to 10 would be children. Let's imagine it could be different. 1 to 6 maybe children, and sometimes people from 10 to 20 could be youth, in case if you're going with the trend analysis, how the youth is traveling, how the average adult is traveling, or the average middle-aged person is traveling, and what's the range of senior citizen. So here we have use cases. So one is children, one is youth, another one is middle-aged, and the other one is senior citizen. So 4 categories there as well. And then here we have gender, and we have address, we have PIN code, and then the PNR of each and every flight, the airlines they're catching up with, and then the aircraft type, so Boeing 787, A380 and all those things, and the category. So on a broader level, on a higher level, the categories could be 2. More than that as well is possible, But let's, for our imagination, let's keep it as domestic and international. Then we have some flight status and subcategories. So in subcategory, we have private, cargo, civil, and sometimes even military could also be involved in that. So they have their separate airport and everything. So let's not consider this. Let's keep it to civil itself. So far, we have private, cargo, and civil aviations, and then the flight status. And here we have flight class, seat capacity. So based on the volume of seats, again, this is artificially generated data set for learning purposes only. The actual data could differ a little bit, not a problem. Now, but working on this data set will definitely give you a very good idea on how to work on the real data sets as well. And if you want to follow along with us, please click the description box below and you will find a Google Drive link so that you can download the data set and then continue with us. And apart from that, we have number of seats vacant. It's not every time that all the seats get occupied in every airline. Sometimes there will be some empty seats as well. Now we have cost per seat, so it is in USD. And then we have revenue generated by the airlines, which is also in USD, and some profits as well. And then the booking websites. So every time you book a ticket, you go through some different websites, right? So here we have Expedia, Booking.com, Skyscanner, Priceline, etc. So these are the columns that we generally have even in real-time dataset as well. And here we have date column. So let's get started with data cleaning. So here I can see my data of date is in year, month, and date format. And if it is in year, month, and date format, then it is pretty much helpful for you. In case if you're transferring this data to SQL database or any of the other BI platforms or any data analytic tools, then most of those data analytics tools prefer the year, month, and date format. So if you don't have it in that format, it's better you convert that. And if you have it already, then you're lucky. But there is a small gray area in this particular data column. We also have timestamps. Most of the scenarios you might have to work with data stamps or timestamps, but here we don't need it. So you can just quickly eliminate them. So here I'll go into short date format, and I have this particular format again in DD, MM, and YY. So I'll go into advanced data formatting, and then here I have custom, and here I have a couple of predefined formats, but I will like to create one of my own. So then it should be okay. So here I have it back again, and I don't have timestamps. But in case if this, since this is artificially created data set, we did not create actual exact timestamps of hour, second, and minutes and all those things. It was just plain 00. So that's the reason we have omitted it. But in case if you're working on real data set, it is one of the parameter again. At what time of the day, at what minute, and everything will matter. So for now, let's keep it that way it is. Now again, we have the next one, region, city, airport. Now comes the customer. So this is again, which needs a little data cleaning. So before we split this, we would like to insert a couple of columns. So one column for the first name, one column for the second name, and the other one would be for the customer ID. So let's keep a column extra for safe side. We can always delete empty columns. Now, here I want it to be split into the customer ID, first name, and last name. So how do I do that? So what I can do is I can implement, there are multiple ways to do it again, but let's implement a few of them. So this is the first name, and this is the last name, right? And now I can employ flash fill. This is one way of doing it. And again, the flash fill. So flash fill worked with the customer ID, but it did not work with the first name and last name. So we understood there is one way of doing it, but now we want a foolproof way of doing it. So what's the foolproof way of doing it? So select the entire column, go to the data section. Here we have an option that says text to columns. Now we have the text here. We want to split that into columns. Now here we have something which says delimited with. So Excel automatically identified that this data is delimited by certain symbol. So in case if it did not identify, then you can go with custom delimiters, or you can also go with fixed width. So where you can fix the width of each and every word or text, character or anything, and then split it. But now let's go with the delimited version. And here, so the delimiter that I have used is not mentioned here. So I'd go with the other option here, and I would mention the hyphen. So here you can already see we have a quick data preview. So if I have option to expand this, I think it's clearly visible. So here we have customer and the first name and the last name. Once you are happy with the preview, you can go to the next. And here, in case if you want to do anything further with the data set, you can do it. And if you're happy with it, you can just finish it. So I'm happy with it and I finished it. So here we have the customer ID, and here I have the customer first name, and here I will be having the customer's last name. So far so good. I did not want this empty column. I'll delete it. And then we have the mobile number. So again, so here what you can do is simply find and replace. The first one which I will be finding and replace is the +1, and I don't want to replace it with anything else. And then we did the 2000 replacements, and here hyphen is the next one I want to replace, and then done. I close this. So this was a simple data cleaning method which is most employed. And again, if you want to do with a little more further implications of data cleaning operations, then I'll link the data cleaning tutorial in Excel, which will give you in-depth understanding of data cleaning. But these are the most common ones which we do on a regular basis, and the simplest ones to easily understand as well. And again, we have the address here. So if you want to, split that from street and city and everything, you can go ahead with that. But now I think address is in the perfect format and the way I need. And I'll look for anything else which I can do. I think these are good enough. But in case if we had profit, revenue, cost per seat, and yeah, we have everything required here. Now our data is good to go. Now you can quickly save this data, and then you can continue with pivot charts and pivot tables. Now to create a pivot table, it's really simple. All you need to do is just select the entire data set and then go into insert option. Here you have the pivot table. From the range I selected in a new worksheet, and done. And now you might be wondering, why did we create a pivot table? So most of the times you might have some in-depth requirements. Let's say your manager asks you to find out the flights based on the region or based on the country. How many number of flights are we having from a certain country to a certain country? Or let's say if you're dealing with domestic flights, since we have considered only American states, let's consider the domestic flights. I want to understand how many number of flights are taking off from a certain city to a certain city, etc. Or how many number of flights from a specific state, right? So in such kind of scenarios, you can do this kind of quick calculation. So I'll have states in rows and then flight details into values. So PNR. So PNR is nothing but the flight. So if you have a PNR, then certainly you will definitely have the count of customers, right? So these many number of unique flyers are flying from respective states, right? And apart from that, if you are looking for a flight delayed status or something like that, then you can also get it. And you can also find out airport code and all those things. So here we have the total count of frequent flyers from all these states. So you can quickly, on a quick glance, you can identify the state of Texas is having, no, the state of Florida is having the highest number of flyers, and Texas is at the second place. Now this is how you create a quick pivot table. And in case if you wanted to create a data visualization for this one, you can go into pivot chart and you can create. Already you can see Excel is recommending you to go ahead with the bar graph, and then you can just click on OK, and you have a quick pivot chart for your pivot data table. Now you can say total, or you can say passengers from cities, different cities. There you go. So this was how you can quickly, clean the data set and create a quick data visualization. This is not a complete dashboard. We just created, or we just skimmed the surface of data analysis in Excel. We just understood the foundational level. But in case, if the same data set is given to you, imagine this is not a complete dashboard. We did not create a full dashboard here. We just created one visualization, which is counting the number of passengers from different cities. Just imagine, in case, if you get such data on a daily level, and we understand the flights fly every day, and you might have to run some numbers and all, find all the visualizations and dashboards every day, and you might have to analyze how your sales performance or anything is doing, right? Would you like to perform these data cleaning? Would you like to create dashboards every single day? No, right? You just need the data to be updated, and you might want to have the data dashboard readily available for you, which is completely interactive and gives you the actual data just by updating the data into the location, right? So this might be a little helpful in real term, right? So let us go through that. So basically what I'm saying is, in case if you're updating the data set or adding the new data to your actual data set, the dashboard should reflect the changes and give you the actual report in an instance. So that's what we're going to explore now. For that, we might have to employ Power Query in Excel. So now let's close this data set as is. And in case if you want to save it, you can save. And then, so here we have the flight dataset, which is an empty folder. Now here in this scenario, this will act as our data source. Now in real time, the data could be anywhere. It could be in a cloud, it could be in an actual database like a Oracle database or something like that. And if you're going with cloud, then you can go with Hadoop, Azure, GCP and everything. And for now, let's consider a simple local data file where all the data set in Excel format has been updated. And this is our data source. Now, I'd like to go with the first data set, which is 2022. I'll just drag and drop it into this particular file. And rest of the files, let's consider these next year files that are 23, 24, 25, 26, and further data sets as the next periodic refreshed data, right? So actually this happens on a daily level, but for now let's consider the year level so that the complexity is minimized. Now I have the first data set loaded in my source. Now what I'll do is I'll go back to Excel, and here I'll create a blank worksheet. So this is my canvas for now. So here you can see data, and here you can see we have a wide variety of data sources. The data can come from a file, the data can come from a database, it can come from clouds such as Azure, GCP, AWS, whichever your preference is. Then you can also come and see that the data can also be from a Power Platform, other data sources, PDFs, combining queries, and all those things, right? So we also have data modeling, where we might have different data schemas and everything, and a lot of those things, right? And now I'd like to go with the other sources, and here, from file, and here I will select from folder. So data can be from an Excel workbook, text, CSV, XML, JSON form, and PDF as well. But now let's take a data source. So we created a file, right? That would be acting as our data source. So I'll go with folder, and here I will navigate to my downloads. Here I have the flight dataset, open, and there you go. So automatically Power Query will be loading on our window. So this is the Power Query window, and then transform the data. So here you can click on the combine files option, which will expand the data. Here you can click on this, and so here you have the preview. So automatically you can see that the date format has been changed, and customer is fine. And here we have the mobile number which we need to work on, and again rest everything seems to be fine. Now click on OK, and then you will have the transformation option. So there you go. Now before we get started, I want to make sure that you understand the few panels here. On the right hand section, you can see Power Query applied some steps for us. Steps in terms of filtering the data, changing the data type and all those things. And you can always click on this into option or the red option, the red X type of logo there, to remove that particular change. And on the left hand side, you can see the queries that Power Query ran for us, right? Now, let's continue with data cleaning in Power Query, right? So the first column is all about the data source, and I don't want it. I will remove it. And here I have the date format. So what I can do is just quickly right click and then go to the change type. And instead of a whole number, which Power Query has already included and performed for us, I don't want whole number. I want it in the form of date. So I'll consider and convert into a date, and then we have region is fine, and yeah. So here we have customer names as well. So what I would do here is I would like to split the column by delimiter, and Power Query has automatically identified the custom delimiter for this particular data set. I'll click on OK, and we will have 3 customer columns, but they are named as customer 1, 2, 3. So let's change that to customer ID, customer first name. You can just double click the column header, or you can right click the column header and change the data name or data type, customer last name. So here you can see A, B, C, right? So that means that this particular data set is text type, and if it is a date type, it is related, right? We have changed it to data type. And in case if we go back to this particular one, age, right? So here we have a numerical value, and pin code is fine, PNR is fine, aircraft type, then the seats capacity occupied, and everything is also fine. The revenue is in terms of USD. You can also kind of add a currency version for that, but for now I'll keep it the way it is. Now, let's say I want to create an age group. So what I'll do, I'll insert a new column. So for that, go to add column, conditional column. If age is less than, let's consider 6 years, then I'd like to have a text format. So children, add clause, if age is less than, if age is less than, let's say 30, then youth, and if age is less than or equal to 60, let's keep it less than, middle-aged, and if the age is greater than or equal to 60, we will keep it as senior citizen. So there you go. Press OK, and then we have the custom column for age group, and there you go, we have renamed it. Now what I'll do is I'll drag and drop this particular column from the very last position to where the customer's data is existing. Let me just drag and drop that. So I think we have the customer details somewhere in the starting section. So we have the PNR here, PIN code, address, gender, age. So I think I'll place it somewhere in between the gender and age group. There you go. Now let's take a quick look. So here we haven't changed the mobile numbers yet. So it is considering as of now as the character value. You can keep it the way it is since you also need the country code. So I'm comfortable with the way it is, and rest, let's have a quick logs, date, region, city, state, airport code, customer ID, customer first name, last name, email address, mobile number, age and age group, gender, address, PIN code, PNR, airline, aircraft type, category, subcategory, flight status, seats occupied and everything. Yeah, so far so good. So now I'm comfortable with the dataset that I have. What I'll do is quickly go to home and close and load. It might take a little while, and there you go. My dataset is all good to go. And here I have all the queries and connections that I have run. Now I can quickly close this and change I don't like this kind of visual, the blue and white color. I like to keep it plain. And if I'm not wrong, I also do have filters for the column headers. So I don't want the column headers. So I'll remove the filters and I'll now change this particular column header to my favorite color. And there you go. And you can also do some table formatting, add all borders to your dataset and everything. So there you go. Now I don't want this sheet. I'll delete this sheet quickly and I'll have the only sheet that I want. Now that we have already understood how to create a pivot chart, I'll quickly create a pivot chart. Go to insert and here you can insert a pivot table and there you go. Now what we'll do is we'll create multiple pivot tables and pivot charts and take all those pivot charts and place them in one single sheet, or also known as dashboard, and add interactivity to it. You might be wondering what happened to the rest of the datasets. I will explain you in the end. Once we create a final interactive dashboard, we can just drag and drop all those extra datasets into the file or the data source location, and the dataset or the dashboard will be interactive and completely recognize the entry. You don't have to create any data cleaning operations like we did on the follow query for the previous dataset. It will automatically consider everything and the background process will run and your data will be cleaned and ready for analysis. All you can see is just the changes in the final dashboard, which is completely automated. Now let's create some pivot charts. So firstly, I'll go with the region and the number of people flying from the region-based analysis. So here we have the region-based pivot chart. Pivot table, basically, I will create a pivot chart for this. So I'd like to go with the pie chart and I'd like to go with the 3D pie chart. And there you go. So I'll rename this as region-based data. And then I'll go to the flight dataset again. I'll select the entire dataset. I'll insert a new pivot table. And you can also rename this as region-wise analysis. In this, I want to go with state-wise analysis. We can also create pivot chart for this. You can go with the recommendation of Excel here. I'll go with naming this as state-wise. And then the flight dataset back again. Select the entire dataset. Insert a pivot chart, pivot table in a new place, and here you can include the airport codes. So multiple cities can have multiple airports. So we can go with state here and airport codes so that we can identify how many number of airports do each and every state has. So I'll insert a pivot chart, or you can also go with a tree map. Number of airports. So here I'll call it as data, and then we will go back to the flights data, create a new chart. Now you can do a gender-wise analysis as well. Insert a pivot chart, gender-wise. There you go. Now let's quickly go back to the dataset and see the further possibilities. Age group, we missed the age group. So what we can do is select the entire dataset, insert pivot chart, and now we will have the age group column. Insert the pivot chart for this as well. Let's go with the recommendation of Excel, and I'll name this as age group. There you go. We can also include timeline. So, okay. Basically, whenever you're dealing with date data type, then understand you can use timeline graph for that. So I'll have date inserted here and PNRs in the columns. So now some error. Yeah. Now I'll create a line graph for this one. So we have an understanding of how frequently or the rise or fall in the travel history, month on month analysis, how the flights are performing. I'll take the same name and rename this sheet as well. And now let's go back to the flight data set. And we can also perform flight or flight service providers as well. So I'll insert a new pivot chart. Now we will select the airlines. So which airline is giving the maximum services, and the PNRs again. You can also go with profit and loss as well. So you can identify which airlines is making highest number of profits. So again, I'd like to go with the recommendation of Excel. You can also customize these visuals, and there are a lot of options and permutations and combinations available. Airline data, and I'll be yes. So we have a couple of pivot charts here readily available for us. Now what we can do is create a dashboard. So I'll click on a new sheet and then rename this as my dashboard. So what I'll do is I'll copy and paste every single pivot chart that we created. Just copy, close this, make some room. There you go. Now we have the dashboard here. I will select any cell and paste. We can also resize based on the requirement. I'll go to the state-wise, copy, dashboard, click any cell, paste it. There you go. So we have state-wise data, airline-based data, and region-wise analysis. So I'll also take the region-wise analysis chart and select any cell, paste it somewhere here. You can also choose to resize this. We have airline data, state-wise data, region-wise data, and gender-wise data. I'll select the gender-wise chart and go to dashboard, and here select any cell, paste it, resize according to the requirements. So we can also go with age group. I'll copy and paste it. And the last one would be month on month flights. So I'll copy this and paste it to this particular cell. So let's say I'm happy with my dashboard here, but now I want interactivity in my dashboard. I want it in such a way where I click on one option and all the dashboard reacts to it, right? So that can be created by using the slicers in Excel. Now here, how to insert a slicer? Just select any of these charts here and then go to pivot area table or pivot chart analyze, and here you can see insert slicer option. So click on that, and here we have a wide variety of slicer options from Excel. So here, repeat. So here we have a wide variety of slicer options here. We can go ahead with the region-wise analysis. We can go with city-wise. We can go with state-wise. We can also go with age group here, and then gender and airline as well. So far so good. We have 1, 2, 3, 4, 5, and 6 slicers. So click on OK, and we have all the slices ready for us right here. Now I'll place all these slicers individually in the dedicated locations where I want them to be. So this would be our first slicer, which is based on airlines. And this would be my second slicer based on age group or gender. You can adjust the sizes. It might take a little while, but it's okay. The first two slices are in position. Just give it a little moment. There you go. Now the rest of these slices. So our age group, I'll place the age group somewhere here. It can even reduce this particular size and position it right here. It might take a little while, or it can even test your patience, but it's completely all right. Unlike the Power BI and other platforms, Excel is a little tricky, but also equally powerful. So not to worry, just give it a little moment and time, and it should resolve all your problems. We are almost at the last slicer, and your report is just one slicer away from being completely interactive. There you go. Now, since you have already selected United Airlines, it is giving you the data related to only United Airlines, or the Southwest Airlines, but not the entire data set. So for that, you might have to select this particular option and go ahead with report connections. And here you need to connect each and every pivot table to each and every other pivot table so that the entire dashboard is completely interactive. So here, there you go. So 1, 2, 3, 4, and 5, 6 pivot tables are connected to each other. Now they interact whenever you select something. So if say I want to go with the male related data only, it will give me the male data and female data here. Or if I wanted to go with children data, then here I have the children related data only, and middle-aged only, senior citizen only. And let's say I want to go ahead with central region analysis, also get the central region analysis here as well. So that's how it is. Okay, we were supposed to report connections to all the other slices as well. That's the reason region-based data was not reacting here. So it might take a little time. So we have connected the airline data but missed the other data tables or data slices as well. So let's take a moment to connect all the other pivot tables to all the other pivot tables. So first pivot table was done, second pivot table was done. Now third one. So all the pivot tables are joined. Let's check this one as again. So report connections. Yes, we have connected everything. And state data, report connections. You can just simply right click and connect the data. Just check in all these boxes and you have established a successful connection. Same with this one, right click, report connections. Check all the data boxes. Okay. And this particular data as well, report connections. Done. So let's check one last time. All the data tables are connected. And this particular slicer, all the data tables are connected. This slicer, the age group slicer, this is also connected. State-wise slicer, this is also connected. We are making sure that no stones are unturned. The next step is to just load the new data, right? So this is also done. Now, let's say I want the children related data set. So I'll have the entirely interactive dashboard working for me. So it will give me children based data from all the airlines, state-wise, age group, month-on-month flights, gender-wise, and region-wise. So let me unselect all the flights or all the filters. Now I want the data only for East region. Now I'll have all the data related from East region, the airline data, state-wise, age group, and month-on-month flights as well. Remove this filter. Now let's say I want only Arizona related data. I'll have the Arizona related data here right on my screen, and can also see month-on-month flights performance, how the flights are being taken and how there is a spike in July on June, July, August regions, and how there is a dip during the end of the month. And all of a sudden, during the December region, you can see the region is growing here. The flight number of flights are taking a rise during the Christmas holidays. That's good. Now, let's remove all the filters and we have the final dashboard as it is. And now comes the part which we were eagerly looking for. What happens to the rest of the data sets? So that's the basic function. So here we had the flight dataset folder, which is our data source here, and it has only one single data entry, right? And if we go back to downloads, the rest of the dataset, which is 2023, 4, 5, and 6, is here, right? And if we open these datasets, again, we have a similar issue. We don't have all the data cleaning done for us. Here we have the date data type, the same timestamps here. And if you go through the customer data set, here we have the same customer ID, first name and last name attached to each other, and the phone numbers. Again, anyways, Power Query was helpful for us here. It did not convert or perform any mathematical operations here. But if you see into the age group, we don't have an age group here. We just have the age here, right? We did not categorize. So you might wonder, do we have to create all that operations again? No. When you have used Power Query, you don't have to perform all these operations again. It has been automated. Now, all you have to do is just copy or drag and drop this data into your data source and done. And come back to your Excel dashboard and you can go through the refresh option somewhere here. So go to data and you will have the refresh option, refresh all. Click on that and done. Automatically, your data will be refreshed. Just give it a moment. Expression key didn't match the row key. Just give it a moment. Go to File, Save, and then go back to Home, Insert. Where is the data? Yeah, here's the data. And now refresh all. Not a problem. So if you go back to data analysis and check, it should be fine. But if you go back to the dashboard, here you can see the variation already. The new data entry has been added and you have the updated data right here. There should be some error in the key function, but it's not a problem. The entire fresh new dataset has been successfully loaded for you via Power Query, and the replication here is already visible on the dashboard. So if you just click on these filters, you can get the data that you were looking for, which is in completely interactive mode. And with that, we have come to an end of this session on Advanced Excel course for beginners. Should you have any queries, then please do let us know in the comment section below. And this particular dataset and all the dashboards will be made available for you. And the link to those is in the description box below.
If you type Tableau desktop download, okay, just type Tableau desktop download. Yeah, Tableau desktop download, you type over here in Google, and then you can go to this area, this link that is download Tableau desktop. Okay, you can click the link here after typing Tableau desktop download. So just like Power BI, you are also having here Tableau desktop. Okay, we had Power BI desktop. Here we are having Tableau desktop. So if you click this link here after typing Tableau desktop download, Tableau desktop, then here you'll come to this area. It says here Tableau desktop, start your free 14-day trial. Now see here, I'll be telling you the difference. Okay, the first difference is coming over here between the Power BI desktop and Tableau desktop. See, Power BI desktop, as you know, that it's a free tool. So it's free for the lifetime. Okay, so that's the best part of Power BI. But Tableau desktop is having a 14-day trial period. So after 14 days, you have to pay money. So here it says download free trial. Okay, definitely we have to go for this one, download free trial. And then when you click on that download free trial, and then the free trial should get downloaded. Okay, it should get downloaded over here. Yeah, so it will take some time here, and once it get downloaded in your system, then please double click that exe file and then you install. Okay, you agree to the terms and conditions, and then you click on install, and then it will get installed. Okay, so installation also will take some time. I would like to tell you one important thing here, that Tableau desktop, as we know, the Tableau desktop is having a 14-day trial period. Okay, now the question will come that, okay, what should I do after 14 days? So if you are a student, okay, now listen to this thing very clearly. If you are a student in a university, then you can get a free license for this Tableau desktop for 1 year. Okay, you'll be getting a 1 year free license if you are a student or if you are a university professor. Okay, so only for these two categories there is a free license, either for the university professor or for the student. So if you are a student, then what you can do that simultaneously, I'm not saying that you wait for 14 days and then you apply for the student license. What you can do here in Google, if I let me make it bigger for you. So here you write down Tableau desktop. Yeah, you see here in my case it is showing me here Tableau desktop download student. Okay, so Tableau desktop download student. If I click it, then here it will take me to, you have to go to this area, Tableau for student. If I click it, Tableau for student. So see, this is the page. If you want, I can also put it in the chat window here. Yeah, so I put up the link in the chat window. You can also use this link if you are a student. And then here it says download Tableau desktop and Tableau prep builder. Okay, now what is this Tableau prep builder that I'll be talking in the presentation here. So here it says get Tableau for free. Okay, so suppose if I click this link here, then what it will ask you here, it says full-time students at accredited credit-bearing academic institutions worldwide are eligible for a free 1 year license to activate Tableau desktop and Tableau prep. Okay, so you'll be getting the license for two products of Tableau. One is Tableau desktop and Tableau prep. In this training program, we'll be focusing only on Tableau desktop. We'll not be using Tableau prep, but it is good that you are having also Tableau prep. Yeah. Complete the form below to confirm your eligibility and unlock your free license. You must be 16 years of age or older to request a license. So here in this form, you have to give all the details. Okay. Also here, it requires your school issued email. So here, if you type your email ID, let's say if I type my email ID samirrodia@gmail.com, it will not accept. Yeah, because it has to be samirrodia@ something university dot edu or something like that. So I have to give my university email ID, not the common email ID. Yeah, general email ID, Yahoo Mail or Gmail. So I have to give this my university mail ID. Yeah, date of birth, blah blah blah, school and everything, and then you click this button, verify student status, and then the details will go to the Tableau. If required, your Tableau will also ask you to send the this your university ID, okay, your identity card. It will also tell you to scan that university identity card and send it to them. Or sometimes they may say, okay, but I would say that today only you apply for this license, okay, and then you can wait for it, and maybe once the new year is there, then you will be getting the license. Okay, these are the important things. Okay, the Tableau desktop is in general it is having 14 days trial period. Now see, suppose if you want to pay for this Tableau license, definitely I'll not tell you to pay for that amount, say pay for this Tableau desktop. But the normal costing of Tableau desktop is around $70 or 70 euros per month per user basis. Yeah, so every month you have to pay $70 or 70 euros. That's the price. Okay, so here I would say that Tableau is having some issue when I compare with Power BI, because Power BI desktop, free tool, you get every month new versions, and you are not paying anything for that. But Tableau desktop, you have to pay money. Okay, but now I'll also show you those who are not university professors or those who are not university students, what you can do. That, see, currently if you have downloaded the latest version, so currently the version which is there for the Tableau desktop, it is 2024. Let me show you that part. Yeah, so this is the Tableau desktop which I've already opened. Yeah, so here if I go to help and then about Tableau, so currently I'm having this. Today only I downloaded this latest version. It is 2024.3.1. Okay, so now see what happens, that suppose after 14 days, if your this Tableau desktop trial will get over. So what I'll suggest you, that those who are not university professors or those who are not students, you can first of all remove the current Tableau desktop from your system. Okay, whatever you have installed, you remove that portion. Yeah, and then again what you do, you go to Google, and in Google you type here Tableau desktop older versions. Tableau desktop older versions. So if you type over here Tableau desktop older versions, then here you can go to this area here. Yeah, see, Tableau is now a say a part of Salesforce company. Okay, we'll talk about that part in the theory, but here it is showing you Salesforce. So here it says downloading previous versions of Tableau desktop. So suppose if I click this thing, so here it comes to downloading previous versions of Tableau desktop or server. I'll go to this area, go to downloads and release note. I click on this portion, downloads. Now see here, these are all the current version is 2024.3.1. Okay, if you want, I can also share this link in the chat window. Yeah, if you want to come over here, you can click the link in the chat window. So the current version is 2024.3.1. Now suppose if this version you have already installed and now it is over, the trial period is over, then you remove this version from your system, from your laptop, and then you come over here to this page. You can save this page for a reference purpose, and now see it is 2024.3. If I click this one, so see in 2024.3 there are again two versions. Okay, this is the latest version .3.1, and that was released in November 21, and before that this new version was also there, another version was also there, that is 2024.3. So what you can do, you can now come to this area on this page, and you can click this version here 2024.3, and then you install this version, the older version, the next older version. You install it and then again use it for 14 days. Okay, I know that this is a tedious process, but this is how you can save your money. Okay, so otherwise if you are ready to pay $70 or 70 euros, I don't mind, but this is what I normally recommend to the participant, that you can go to the next older version. So now if you download this version and if you use it for 14 days, again you remove that version, again you come to this area, and now you can go to 2024.2. Now see, up till, if you are going till let's say 2023 also, this version, then you don't have any problem. Okay, because normally we think that, oh, if I'm going to the older version, then definitely I'll be not having all the latest features. But as such in Tableau, this is my personal feeling, that in Tableau they are not changing so much things in Tableau. Okay, in Power BI what happened, that every version is having something new, but in Tableau the changes are not that much drastic. So even if you one by one, if you go see for 2024.2 also, if you click it, there are so many versions. You can use this version, for every version you can use it for 14 days. Okay, likewise 2024.1 and so on. Okay, so this is how you can save your money. And at least I would say that, see, just now you have to focus on this course. Okay, you try to have this Tableau desktop for this course. Okay, and then after the course is over, if you are in the organization and if you want to do something more with the Tableau, then definitely you can ask your organization and they will pay the money for you. Okay, but at least just now for this course you have to go like this. Okay, those who are not having this. Now this is Tableau desktop. Okay, so in case of Tableau, they also have one more version, another tool which is known as Tableau Public. So suppose if I write down here Tableau Public download. Okay, Tableau Public download. Now what is this Tableau Public here? Tableau Public, remember that it's a free version. Okay, and it is free for the lifetime. Just like Tableau, just like Power BI desktop, here they are having Tableau Public. So here you don't pay anything, and here you don't have any problem of trial period. Okay, so this is also another tool, especially for this training. I would say for especially for this training, you can go for Tableau Public also. Okay. So I'll tell you what is the limitation over here, definitely, because whatever is free, it is, yeah, there is no free lunch in this world, as we know. So whatever is free, it will not have all the features, but I'll tell you, yeah, the exact difference over here. But Tableau Public also, what I would suggest you that just now you go for Tableau Desktop, you use it for 14 days. After 14 days, if you want to still use Tableau Desktop, I already shown you the method of going to the older versions. If not, then you can come to this Tableau Public, and here we are having this link Tableau download Tableau Public. If I click it, okay, so normally here I think so I'll show you exact link, because somewhere will be finding the link here, the Tableau Public, Tableau Public here, let me see. Yes, this is the Tableau Public. Tableau Public is a free platform to explore, create, and publicly share data visualizations online. With the largest repository of blah blah blah, yeah, Tableau Public makes data skills this thing. Okay, so this is the button, Tableau Public. Maybe you can also download this parallelly along with your Tableau desktop also, because see, sometimes if your Tableau desktop is over, at least you are having the backup of Tableau Public, I would say. Yeah, so this also you download immediately. Yeah, click on this link, go to Tableau Public, and then definitely here also it will ask you to sign in. Yeah, here it says sign up for Tableau Public. If I click it, then here I have to give here my first name, last name, email. Now see here email, you can give your Gmail or Yahoo Mail also. Okay, here they don't require a professional mail ID. So in the Tableau Public, you can, if you want to create your account, you can create your account with your Gmail ID or Yahoo Mail ID or any other general mail. Okay, so give your last name, first name, email, password, concern password, and it will create a account, and then from there it will start downloading. Okay, maybe after you put all these details, then it will show you download download Tableau Public. You click on that button, and then it will download that Tableau Public, and then you install it. Okay, so two tools you have to install one by one today: Tableau Desktop and Tableau Public. Benefits of data visualization, let us quickly see. So quick and clear understanding of the information. As I said, as I mentioned earlier, that whenever you see a visualization, you are able to get the information very quickly, and you are also able to remember that visualization. So quick and clear understanding of the information. Second benefit of data visualization is identify emerging trends and act quickly based on what we see. Yeah. So this is a great benefit of data visualization, identifying emerging trends. Now see, whenever I'm conducting the sessions, let's say Power BI sessions or Tableau sessions for the mostly for the US and Canadian participants, yeah, on another platform. So there I always give the example. In this second point, I give the example of India. Okay, that we were. I think so. This also we discussed maybe in the business analytics portion also, business analytics with Excel. That after the COVID, two major things happened in India. First one was the digital payment. Yeah, everywhere people were just scanning the QR code or barcode and they were paying the money. Yeah, which was great, and up till now also the things are going on very well. And the second thing was this online sessions. Yeah, especially for the universities, because I was associated with many universities, but I was not able to conduct the online sessions before the COVID. Yeah, because there was no trend. I'm not saying that there was no technology. There was no trend of conducting the online sessions in the university, especially. Yeah, for this kind of Simplilearn courses and this thing, we were having the things, but for university there were no online courses, online sessions. So that also happened. Yeah, thanks goes to COVID. And since 2020, yeah, after this COVID, uh, I'm regularly conducting the online sessions for the students, also for the university students, okay, up till now. So that is the major thing which has happened. And for the digital payment, okay, I always give this digital payment example even to my German colleagues also, that here in Germany also still people are believing in the hard cash. Many people, though definitely many, or many of the shops, they are taking the credit cards and debit cards, but still many people, they are having the cash. Okay, they believe in cash. Even just now we are having the Christmas market and all those things. In Christmas market, I don't know, hardly I've seen one or two stores, one or two, yeah, shops over here in the Christmas market with their okay, where they are accepting the credit cards or debit cards. Otherwise it's fully on the cash. I don't know about other countries, yeah, whether the same thing is there, but here mostly people are going for the cash. So what happened, that when that COVID came, so it brought many challenges, yeah? And those who accepted those challenges and they came out with some solution, they are still there in the market. Yeah, I remember that I'm coming from a city known as Vadodara in Gujarat. And earlier when I used to visit my city, my state, I used to go to some specific restaurants. Okay, yeah, because they were famous for good food. But when I went after COVID, many of those my good restaurants, they were closed down. They were completely shut down. Okay, I don't know what was the reason, but one of the reason was that what I came to know was that they did not accepted the new change. Yeah, initially people, they were not going to the restaurants. They were having everything online. Yeah, everything was delivered. But these restaurants, they somehow they insisted that no, we have to bring here the people rather than the delivery. So those who did not accepted the change, they were out of the market. And also it happened in my city that many of the new restaurants also got opened during the COVID time, and they are still there. Yeah, because they accepted this new trend. Okay, so whatever this example which I'm giving here, this example also applies to us. Yeah, to our own life, that if whatever the new things which are coming in the data analytics or business analytics, if we are not accepting those changes, we'll be also out of the market. Yeah, just like those restaurants. So today we are talking about generative AI, tomorrow we'll be talking about something else. We have to continuously learn these new tools. That is what is my thing. Okay, and I'm also doing the same thing. Yeah. So emerging trends we can quickly identify with the help of data visualization, and we can implement it. Then the number three is identify the relationships and patterns. So we can see that, okay, if our sales have gone down, then why the sales have gone down? What are the reasons for that lower sales? So that we can easily identify with the visualization. The fourth benefit over here is share our story with others. So share our story with others. Now, what is the story here? Story means we are talking about the report or the dashboard. Yeah, now you know that in every organization everybody will not be creating the dashboard, everybody will not be creating the Power BI report. Few people will be creating the report and the other people will be utilizing that report. Yeah, so here sharing our story means if I create my report, then definitely I have to share with my colleagues. So I have to share my story with other people. So in case of Tableau also I'll be showing, and in Tableau it is little bit different compared to Power BI. Yeah, so that also will discuss that where this Power BI and Tableau are different in terms of creating the report and creating the dashboard. Okay, so when that particular topic will come up, I'll tell you these differences. Number fifth is analysis at various levels of detail. Analysis at various levels of details means, suppose if I'm working in a MNC company, so definitely I'll be having the we were talking about this analysis at various levels of detail. So we start from US we go to the state, from state we go to the city, and within the city also we are having the various areas. So we are having the postal code or pin code, so we go to that area level. So this is what we mean by analysis at various levels of detail, and in short it is known as hierarchy. Okay, so that is that hierarchy topic. And the last point over here, the last benefit is improved customer experience and engagement. Now whatever we have seen up till now, all the benefits, why we are doing all those things, why we are sharing our story, why we are doing the analysis at various levels of detail, because we want to give the best experience to our customer. We want to make them satisfied. We want, or we want to make them happy. Yeah, because if the customers are happy, if the customers are engaged with our company, overall we are also happy. It's a win-win situation. So in general, these are the benefits of data visualization. Yeah. Now I'll not talk about Power BI, just skip this thing. But what I wanted to show you here, that this is the magic quadrant. I don't know whether you saw it in your Power BI course. This is the magic quadrant for analytics and business intelligence platform. Now, who has created this magic quadrant? The magic quadrant has been created by this company known as Gartner. Okay, so Gartner, I think so you must have heard this company name. If not, then I would like to inform you that this Gartner is a very famous research company. They are conducting a lot of research over here. So they are, every year they are creating their own report, and then there are companies who are buying those reports. Okay, these reports are not free of cost, you have to pay for it. So here I want to highlight that what is the scenario of those various data visualization products that we are having in the market. So this is the scenario which was there in 2022. Yeah, so we'll see the scenario of 2022, 2023, and the latest scenario in 2024. So in 2022, you can see that in this magic quadrant, we are having these 4 quadrants. So we are having the leaders section, challenger section, niche players, and the visionaries. If you focus on the leaders section, the leaders in this data visualization area, here it is written Microsoft. And then it is written here Salesforce bracket Tableau. And the third leader is Click. I'm sure that you must have heard this Click company. Click is a very famous data visualization company in US, but their products are used worldwide. So Click is having 2 products. Initially, they were having Click View, and the latest product is the Click Sense. Yeah. So I have also learned that tool, Click Sense and Click View, though I'm not using regularly here. Now here comes Microsoft. Now see, I initially told you that Power BI is currently number 1 tool in the data visualization market. But now see, here it is not written Power BI, it is written here Microsoft. Why? Microsoft, why it is written Microsoft? Because definitely Microsoft is not having one tool, that is Power BI. But if I just talk about data visualization tool, then the data visualization tool, Microsoft is having 2 products. First one is Excel, as we know very well, and the second one is Power BI. Okay, so Excel came almost like 30 years before, or 35 years before. So, and today also people are still using Excel for the data analysis, for visualization purpose, everything. So that's why here they have not specifically mentioned Power BI, but they have mentioned here Microsoft. Yeah. But overall, I would say that I'll repeat that sentence, that Power BI is currently number 1 tool in the data visualization market. Then comes Tableau, and then comes Click, and then these are the other tools. You see that I was talking about this tool, MicroStrategy. In 2022, it was in the niche player segment. Yeah. Then Google was here, challenger section. Google is having Google Looker Studio. Initially, Google changed the name to Google Data Studio, but then this year only, they changed it to Google Looker Studio. So I have also learned that tool. Yeah. So see, that is the advantage that we also all get this thing, that if you know one tool, you can learn the other tools very easily. Yeah. Just remember that their look and feel effect is different. And definitely some of the features which are available in Power BI will not be available in Tableau, or the features which are available in Tableau, they will not be available in Power BI. So you have to understand only those features which are not common. Now in 2023, what was the scenario? The scenario was same. Microsoft was number one, Salesforce Tableau was number two, and Click was number three. Yeah, here little bit you can see that this micro strategy, which was in niche player, now it has shifted to challengers. It shifted to challengers here in 2023. Yeah, maybe this Alibaba Cloud, it also came over here. So some changes occurred over here. Now let us focus on 2024, the current year. So in current year, you see here the scenario leaders section. See, so many leaders are now here. Microsoft, Tableau, Click is over here. Google has come now here. Yeah, now so now I know that some of the companies have shifted to Google Looker Studio because it is also cheaper. Yeah, everything comes to the price initially. Then we are having here Oracle and ThoughtSpot. ThoughtSpot is also is a tool, famous tool. So see, now you can see that Tableau is facing lot of competition here. Definitely it is also this Power BI is also facing competition, but here all these tools are nearby Tableau. Yeah. So whenever a company wants to decide which is the best tool or which is the second best tool, then now company has to think over these other tools also. So that's why when I saw this figure for the first time, I was really astonished. Yeah, because till 2023 and 2022, you see the 2022 2023, the scenario was almost same, especially for the leaders section. But as soon as we went to 2024, the things changed here. And now I don't know what will happen in 2025. Maybe some other one or two tools will come over here. You never know. So this is what I wanted to highlight here. That is how this data visualization market is moving. So now we'll be focusing really on the topic of Tableau. Okay. So Tableau data visualization tool. Okay. And it is very popular among the users. Now what it says here, Tableaus allow us to evaluate raw data in the form of graphs and report. Yeah. So initially we create some graph or some charts. And then what we do, then we put all those graphs and charts into one particular page. And that page is known as dashboard. Okay. Just I would like to ask you one question here, that you have all used Power BI desktop. Okay. So I would like to ask you one question, that whatever the visualizations you are creating in Power BI desktop, that whole file, okay, that whatever that Power BI file that you are creating, Power BI desktop file which you are creating, yeah, that is having an extension of .pbix. So what is that Power BI file known as? That's my question. Yeah, that Power BI file is having many pages. You must have created various pages. So what is the name given to that whole concept of that file? Okay, what is that whole file known as in Power BI? So it's known as report. Yeah, so that should be very clear. That whole Power BI file which we create in the Power BI desktop, it is known as Power BI report. Why I'm stressing this point? Because many people, they also mention it as a dashboard. That is not a dashboard. Okay, in Power BI desktop you cannot create a dashboard, and normally the dashboard is of one page only. Dashboard will have only one page, while in the Power BI file we are creating various pages. So that is known as a report. Okay, so you should be very clear over here. Yeah. Now I would like to ask you that where we can create dashboard in Power BI. Suppose if I want to create a dashboard in Power BI, where should I create? Okay, so now the answer for this question is this, that where I can create the Power BI dashboard. Power BI dashboard can be created only in Power BI services. I repeat, Power BI dashboard can only be created in Power BI services. It cannot be created in Power BI desktop. In Power BI desktop, we create only Power BI report. Yeah, that's why I asked this question. I wanted to clear this confusion. Yeah, because many people they say, oh, see, many people they feel that dashboard and report are same. No, in case of Power BI, it is totally different. Yeah, so you must have, yeah, in your online session, you must have been shown that how we can create a dashboard in the Power BI services. Yeah, I hope that you must have been shown this thing. Yeah, how to create the dashboard in Power BI services, if I'm not wrong. Yeah, that you should know the concept. Okay. So dashboards are always created in Power BI services. That Power BI services, as you know, that it's an online platform. Okay, where suppose if I want to share my report with my colleagues, then I have to publish that Power BI report into the Power BI services, and then from there Power BI services I can provide the access. I can say that okay, I want to give access to, let's say, Diksha. Okay, so I'll write down the email ID of Diksha, or let's say Clifton or Henry or whoever. Yeah, and then you will be able to see my report in the thing. And dashboard also I can create in the Power BI services. And what I do that from the Power BI report, I can take some few visualizations from the report and I can put it into the dashboard. Okay, so this is what is Power BI. Okay, now in case of Tableau, in Tableau we don't have the concept of Tableau report. We have the concept of in the Tableau. We'll be now mostly tomorrow onwards we'll try to see that in Tableau what happened, that on one page I can create one visualization. I repeat, on Tableau, in Tableau desktop or in Tableau public, whichever tool you use, on one sheet, yeah, I can create only one visualization. While in case of Power BI, on one page you can create many visualizations. Yeah, so that is where the difference now is coming up here. Yeah, so in case of Tableau, I create 10 sheets. 10 sheets means 10 visualizations, let's say. And then in the Tableau desktop or Tableau public, I'm having a separate section which is known as Tableau dashboard. So Tableau dashboard, if I want to create, I don't have to go to any other online platform. I can do it in the Tableau desktop or Tableau public. So in the Tableau dashboard, I bring all the visualizations, okay, and I can put it into one place, and that is what is meant by Tableau dashboard. Okay, so here this difference comes up between the Power BI and Tableau. Yeah, so that is what. So here in case of Tableau also will be creating these kind of yeah, here they have used the word report, but it's not actually the report, it's a Tableau dashboard where you can bring all the visualizations together. Data can be in the form of big data, Hadoop, SQL, cloud based cloud data, anything can be there. Okay, and all the data can be brought into Tableau, that we'll see further in the practical part. Tableau software does not require any technical or programming experience, that I've already explained you earlier. Yeah, Tableau is user friendly, which is a great skill for data science, applicable to any business, fast and easy. Yeah, many of the things are getting repeated over here. I will skip this portion. Okay, now what we'll do that before we go with this concept of data blending and other things, now let me focus on the Tableau. Okay, so if you have already downloaded the Tableau and installed the Tableau, please open. Either you can open Tableau desktop or Tableau public, or both also, it's fine. So see, when you open, when you double click the Tableau desktop, you will get this kind of screen. See this portion here you'll not be able to see anything. Yeah, because these are the files which are already created by me. Yeah, so that's why, yeah, you can see there. See, these are some of the files which are created by my students in one of the Indian university. So when I opened it, yeah, I can also click this file directly, and I can open this Tableau here. So initially in your case, you will not be able to see anything here. Now on the left hand side here, you are having this area which is known as connect. Okay. So in the case of connect area, you are having here Tableau server. So see, in many of the big organizations, what they do that they also purchase Tableau server. Yeah. In case of Tableau, they are having two products here, Tableau server and Tableau online. Yeah. So suppose if I want to share my visualizations, or if I want to share my Tableau file with my colleagues, then I'm having two options here. Either I can purchase the Tableau online, okay, or I can purchase the Tableau server. Now, if I'm working in a smaller organization, yeah, in smaller organizations, the number of users will be very less. Let's say there are 10 people or 50 people, let's say. So in that case, I will not be able to go for Tableau server because Tableau server is very, very expensive. I don't know the exact price over here, but Tableau servers are very, very expensive. So it is only useful for very, very large organization. Yeah, those organizations which are having some little bit of doubt about the security of their data, yeah, and all those things, for them, if they go for Tableau server, then it is fine. Yeah, they can pay the money also, and plus they are having large number of users. So Tableau server, they can buy it, and then they can put all their visualizations, all their data set on the Tableau server. Yeah. So if I want to connect to Tableau server, I can click on it, and then it will show me here the I have to write down the server name. I have to click on connect, and then I have to give my username and password, and then I can connect to the Tableau server. I can bring the data from the Tableau server. I can connect with the Tableau desktop, and then I can start my visualization process here. Okay, so that is what we mean by the Tableau server here. Then we are having this portion here, which is known as a to a file. So in the file, we are having options like Microsoft Excel. Yeah, if you are having a data set, let's say our majority of our data set are in Excel, so we'll be mostly using this button here known as Microsoft Excel. So if I click on Microsoft Excel, yeah, I'm just clicking on Microsoft Excel here, and now I can go to any of this file. I can bring the data from any of this Excel file. I can connect over here. Yeah, we'll also see further. Not now. I'm not showing you everything here just now, but I can connect any Excel file to Tableau by clicking this button. Then we are having text file. Either you say text file or CSV file. This is that option that we have to click. Then we are having JSON file, Microsoft Access, PDF file. If you are having the data in PDF also, you can connect that PDF file to Tableau and you can bring the data over here. Then spatial file. I think so. Spatial file is related to some geographical file. I think so. I'm not, yeah, because I'm not using that file so much. But yeah, it is related to the geographical data. And then we are having the statistical file. Statistical file here, this is very, very important option. See, you must have heard about one tool, one statistical tool, which is known as SPSS. I repeat, SPSS. Yeah, I have used that tool during my PhD work. So SPSS stands for Statistical Package for Social Science. Yeah, it's a tool from IBM, and there you can do any kind of statistical analysis, yeah, t-test and f-test and all those different kind of testing, hypothesis testing, yeah, regression analysis and correlation and all those things. So it's a very famous tool, especially I know that in India it's very, very famous. And similar to that SPSS, there is another tool which is known as SAS. Yeah, SAS. Yeah, it's known. Yeah, it is always spelled as SAS only. So SAS is more famous in other countries. Yeah, in India, I'm not sure whether it is still famous, but yeah, SPSS in most of the universities I know that they use SPSS. So suppose if you have created an SPSS file. Now see, SPSS is great for the statistical analysis, but if you want to create visualizations, then definitely you can use the Tableau. So you can create a statistical file from your SPSS, okay, and then you can connect that statistical file to Tableau by clicking this button over here. Yeah, so and I think so in Power BI, up till now what I know that in Power BI you are not having this option to connect the SPSS file to Power BI. But in Tableau they are having this option. Yeah. Then we are having here more. More means if you are having something else, let's say you are having XML file, suppose XML, your data is in XML file, you can click on more and then you can connect to that particular file. Let's say XML file. Okay, you can connect over here. So these are the file options. Then comes server options. So in the server, we are having here Microsoft SQL Server, MySQL, Oracle, Amazon Redshift. These are the standard servers which we use. But apart from that, we also have here more. Okay, so suppose if I click on more, you see here, there are so many options here. These are installed connectors. So see, there are a lot of here Alibaba, Amazon Athena, Azure, yeah, Cloudera, Databricks, yeah, Dremio, Dropbox. You see, many Google. So these are various options. If you click on this more here, yeah, and also there are some additional connectors. Yeah, there are install connectors are 71, additional connectors are 38. These are very specific here. Exasol, Denodo, okay, Delta, and many more. Salesforce, Marketing Cloud by Tableau. Okay, so there are many options here. So when you click on more, you get all these options here. Yeah. So this is the Tableau desktop. Yeah, these are the options which you get in Tableau desktop. Apart from that, you also have here quick start. Okay, what is this quick start here? In the quick start here, it says jumpstart your analysis with pre-built template. So see, in case of Excel also we have the templates. So if I don't want to really create everything from scratch, I want to use some template, then these templates are also available over here, like Salesforce, Sales Cloud, okay, budget controlling, retail sales, call center, agent analytics. You have to just connect your data with this file, and then it will be done. Everything will be done. Okay. So if I click on view more, yeah, I have clicked on this view more here, and now here, these are the various analysis which are already created. Yeah, financial performance dashboard. Yeah, Salesforce, Databricks. Yeah, see, there are so many options here. It's a very long list here. So you can also use these templates here. Yeah, you can use these templates over here, the ready, the built-in templates, and you have to just connect the data, and the visualizations are ready. So this will save a lot of your time. Yeah. Then there are these two sample workbooks. Okay. So just like if you remember that in case of Power BI also, we have one sample data set button in the Power BI, if you remember. So in case of Tableau also, you are having these two data sets. One is known as Superstore data set, and another one is known as World Indicator. And plus here below, it will show you the latest Tableau version. Yeah, if you let's say if you are opening this Tableau after 2 months, suppose, and in the next 2 months, if one new version has come up, then here it will show you that now you can download the so and so version. Okay, so here you'll be getting that information about the new version. Okay, definitely if you go to the Tableau desktop also, there also you'll be getting that information, but normally we don't go to the Tableau desktop. Yeah, we open this because today only I opened this Tableau desktop, this tool, and I saw that a new version was there, so I implemented, I downloaded that new version here. Okay, so this is overview of that Tableau desktop. Let me show you here Tableau public. So this is Tableau public. Yeah, here it is already written Tableau public. So in Tableau desktop, it will be written like this only, Tableau book 1. See, in my case also, I'm having currently the license version. So here it says Tableau license expires in 14 days because today only I've installed. And very soon I'll be also getting that free license for 1 year. Yeah. So then I can, I can input that license code, and I can extend my license here. So this is when it is not written here any Tableau public, then this is your Tableau desktop. And now this is Tableau public. Yeah, as I requested earlier that please also download this tool. Okay, because if sometimes if the Tableau desktop is not working, at least you can work with Tableau public for this particular training course I'm talking about. Here also you can see that, see, in the Tableau public, you don't have that option of the Tableau server. So here in the Tableau public, you are having all those options here. See, here we don't have that option of Tableau server. You can see here, there is no option of Tableau server. While in case of Tableau desktop, I'm having that option. So see, this is also one of the difference here. So these are the standard options here in the Tableau public: Excel, text file, JSON file, Microsoft Access, PDF, spatial file, statistical file. Now see here, if I'm having XML file, if I'm having the data in XML, I cannot connect over here with the Tableau public. I can connect only these 7 files here. Yeah. Then to a server. In the server, I'm having option of OData and more. If I click on more, you see here, in the Tableau public, I'm having only these 3 connectors. Only 3. Okay. Google Drive, OData, and Web Data Connector. That's all. I've never used this Web Data Connector. Yeah, and OData also, I mostly use the Google Drive here if I want to connect it over there. But now you see that now this is the first comparison here. In the Tableau, this is my Tableau desktop. If I click on more here in the server, I see here how many? 71 plus 38. Okay, so 109 connectors I'm having here. 109 in the Tableau desktop. While in the Tableau public, I'm having only 3 connectors here. So remember that Tableau public is only used for the training purpose, nothing else. If you want to really use it in your organization, you have to always go for the Tableau desktop. Yeah, because normally in companies, we are mostly connecting the data from the Tableau, say from the various server. Either it can be SQL server or Oracle server or IBM server. Yeah, definitely we also use the Excel files and CSV files and all those things. But here, in that case of Tableau public, I'm not having that option of connecting to SQL server or Oracle server or IBM server. Yeah, so this is one of the major limitation here between the Tableau in the Tableau public here. What's the point? So what I was talking here, that we will be connecting this file here, sample superstore 2024.xls. You already downloaded in one of your folder. So we'll be connecting from the folder. Okay, we cannot connect from here, from the LMS. It's not possible. So in this Excel Tableau desktop file, I'll be clicking on Microsoft Excel. Okay, I click on Microsoft Excel here, and now I have to go to that folder. Okay, so I go to that folder. Let me go to my D drive. Okay, Simplilearn, Tableau course, data files. And here I'm having that file, sample superstore 2024. You can connect that sample superstore 2024 wherever it is available. I click on open. Yeah. And now here you are having the another window. You see here, now it is a different window. When we were clicking on the Excel file, Microsoft Excel, that was another window, connect window. Yeah. And now when we already connected that sample superstore 2024 data set with this Tableau, now you are getting this window. So here on the top area, you can see sample superstore 2024, the file name. It is written below Microsoft Excel. Now in this file, you are having these 3 sheets here. Okay, there are 3 sheets. So we are having order sheet, people sheet, and return sheet. Now let me show you that file also, Excel file. So in this data set, I'll make it bigger. Okay. So in this data set, we are having various. First of all, you can see below on my screen that we are having these 3 sheets over here: order sheet, people sheet, and return sheet. Yeah. So there are the 3 sheets over here. The major sheet is the order sheet. Yeah. In most of our this practical part will be using the order sheet, but just now I want to also talk about these other 2 sheets also. But in the order sheet, you are having here various orders. Okay, so we are having here, first of all, columns like row ID. row ID, you can see that it goes till what? How much? 10,000. Yeah, the number of records are 10,194. Okay, so this is the number of records that we are having in this data set. Then we are having here order ID. Order ID, as you can see, that it is consisting of the country code, then year, and this number. Okay, so this whole thing is your order ID here. Yeah, then here, yes, it is containing both the Canada data and the US data, as I mentioned earlier. Okay, so this is US. Maybe in between also there is some Canada data here. Yeah, so yeah, order ID. Okay, then we are having order date, ship date. There are two dates over here, order date and ship date here. Then we are having here the ship mode. So here, if we see the ship mode, then in the ship mode, we are having four ship modes here: first class, same day, second class, and standard class. So four ship modes are over here. Yeah. So here we are having the customer ID. Then we are having the customer name. Okay, customer name here, it is combination of both first name and last name. Then we are having the segment here. Okay, segment, we are having here three segments: consumer segment, corporate, and home office. Then we are having here country, as I said, Canada and United States. Then we are having cities, various cities. Yeah. Then postal code, region. Now in region, we are having here four regions: central, east, south, and west. Okay, so there are four regions over here. Yeah. Then we are having the product ID. Okay, so this is the product ID here. Then we are having here category. Now this is important. Okay, so in our data, we are having the three categories here: furniture, office supplies, and technology. And then after the category, we are having here subcategories. So subcategories here, if you count, it should be 17. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10, 11, 12, 13, 14, 15, 16, 17. Yeah. So there are 17 subcategories here. Accessories, appliances, blah, blah, blah. Okay. So here you can understand that there is a hierarchy. What is the hierarchy here? First of all, we are having on the top category. So there are three categories: furniture, office supplies, and technology. Within the category, we are having the subcategories. So you will see further in our visualization also, we are having various subcategories. So under each category, there are some subcategories. And under each subcategory, there are various products. Okay, so there are various product names. Here we are having the product name column, the last one of the column here, product name. So this is the hierarchy here: category, then subcategory, below category we are having subcategory, and below subcategory we are having the product. Okay, so this is what we are having here. Then finally, after the product, these are the various product names. Then at the end, we are having these four columns here, four numerical columns: sales, quantity, discount, and profit. Yeah. So these are the four numerical columns that we are having here: sales, quantity, discount, and profit. Yeah. So that will be also using. So these are all the columns which are available in your this orders table here, or order sheet here. Now we go to the people sheet here. Let me make it bigger for you. People sheet. In the people sheet, I'm having here managers, regional managers, and the region. Okay. So there are four regional managers for four regions here. Okay. Now see here, this column, region column in the people's table or people sheet, the region column is there: west, east, central, south. And the same column is also available in your orders table. I've already shown you the region column in the orders table here. Okay, so just remember that this is the common column between the two tables here. Between the people's table and the orders table, there is a common column which is known as region column. Just remember this point. So this is people's table, then comes the returns table. returns table or return sheet. Return sheet means in this returns table, it is having the details about all those order IDs which are returned by the customer because they are not happy with that product. Yeah, as we know that in case of Amazon, there is a 30-day return policy. So here, all these order IDs, okay, all these orders which have been written by the customer, their details are over here. So here there are only two columns in the returns table, that is returned. Yeah, everywhere it will be yes, yes, yes. Okay. So these are the return or say return column and the order ID column. Now see this order ID which is available in the returns table, the same order ID is also available in your orders table. Yeah, I already shown you this orders table, the order ID, the second column here. So also remember the second point here that there is a common field between the orders table and the returns table, and that common field is known as order ID. Yeah. So this is a common field, and between the orders table and the people's table, we are having the common field which is known as region field. Okay. So this is what I wanted to highlight here. I'll close this file. Don't save. Okay. So here on the left hand side, now I'm back in the Tableau. So on the left hand side here, just hold on. Yeah. So on the left hand side here, you can see these three sheets here. Okay. Three sheets here. These are getting repeated here. Don't worry about that. But these are the three sheets here: order sheet, people sheet, and return sheet. Yeah. Now what it says here in the center area, it says drag tables here to create a data model. So now I have to see, let's say I'm having here three sheets. Now, if I want to use here, let's say order sheet here as a data set, then I have to drag this order sheet and I have to place it over here in the center area. So now I'll request all of you to simply drag this order sheet with your mouse, drag the order sheet, and you drop it over here on this area. Okay, so drop this order sheet, drag it and drop it over here. So see, when you drop it over here in the middle area, then you can see that now the order sheet is over here. Okay, and now here you can see this is the table. Now see, there are two tables over here. This table, what you see on the left hand side here, this table, this is known as metadata. This table is known as metadata. Again, I'm repeating what we have to done here. We have simply drag this order sheet and put it over here on the blank area. Okay, and then these things will come up here. So this first table, it is known as metadata. What is metadata? Metadata, in simple words, it is data about data. So if I want to know that how many columns are there, what are their names, and then from which table they have come up, then this information is available over here in this metadata. So here we are having 4 columns in the metadata table, that is type. What is this type over here? These are the data types here. In Power BI also, you must have gone through the data types like text data type, date data type, time data type, whole number, decimal number, fixed decimal number. Yeah. So whatever the data types you have learned in Power BI, almost the similar data types are also available here in the Tableau. So this type means the data type column. Okay. We'll also see further this thing. Yeah. ABC. I think so in Power BI also you must have seen that ABC. ABC means the text data type. Here it is known as string data type. The name is different. In Power BI, it was known as text data type. Here it is known as string data type, this ABC. Yeah. While these are the icons of the date. Yeah, because order date and ship date, these are dates. So these are their icons. And when you see this hashtag here, hashtag means we are talking about the numbers. Now numbers can be both whole number and decimal number. Yeah. So this is the symbol or icon for the numerical field. Okay, numerical field. It can be decimal or whole number, but the icon is same here. Then we are having the globe icon here. Globe icon means these are the geographical field. In case of Power BI also we have the geographical field which are identified by the globe icon. Yeah. So country oblique region, city, state oblique province, postal code. These are all the geographical field, and these are already identified very well by Tableau. We don't have to do anything here. Now at the bottom area, you can see there's our 4 numerical fields, as we have seen in the original data set also: sales, quantity, discount, and profit. Now here also we have the hashtag. Okay. Now if you see that here the colors are green color. These 4 hashtags are having green color. While above, if you see this row ID, yeah, row ID is also a number, so it is having a blue hashtag. So see, though it is a hashtag, but it is identified, it is shown in 2 different colors. One is blue, another one is the green color. So what is this blue and green? That also we'll see further. Yeah, because it is indicating something over here. Yeah, they have not just made it look beautiful. Yeah, it is having some purpose here of this green color and the blue color. So that we'll see further. So here we are able to see the type, then the field name. These are the field names: row ID, order ID, blah blah blah. Then we have the table, physical table. So currently what we have done, we have dragged only one table, and the table name is order sheet or orders table. So here everywhere you will find orders, orders, orders. Suppose if we will also bring very soon this people's table, and then here you'll be also finding the fields of the people's table, and you'll be also able to see here the physical table. In the physical table column, that is the people's table or returns table, if we are bringing this table over here. Yeah. Then we are having here a remote field. So there is another column here which is known as remote field. So see, remote field name, if you see, if you compare the field name with the remote field name column, they are exactly same here. Row ID, row ID, order ID, order ID, order date, order date. So now the question will come that why Tableau has given these different names over here. Why we are having these 2 separate columns? So if the field names are same, then what is the logic here of giving these 2 columns here? Yeah. So that also we'll see now. So this is the metadata. Okay, metadata table here, where we can get a quick overview about our data set. Just now we don't require this metadata. So if you don't want to see this metadata table, you can click this icon here, this icon, the arrow. I can click on it, and when I click on it, now it is getting collapsed. Okay, see, this is that button. So click on it, and it get the metadata table get collapsed. Now this is our main table. Okay, so in the main table, we can see all these columns that we saw in the original data set also. All the columns are available over here. Okay, and their icons are also available on the top. Yeah, the globe icons, ABC, ABC. Yeah, that is the text data type. Okay, so this is the data set. Now, just now here, how many records are shown? Here you can see the number of records or number of rows. How many it is showing you currently here? 100 rows only. 100 rows. Okay. Now, how many records we are actually having? More than 10,000, 10,100 something. Okay, 10,200 approximately we are having records or number of rows, but here it is showing you only initial 100 rows. Yeah. So in case of Power BI also, if you remember that when we are connecting a data set and when we go to the Power Query Editor window, there also we can see the initial 1000 rows, not all records. Yeah. So if I want to do the data analysis here, I can see definitely all the records are connected to Power BI, but in case of Power BI, it will show you initial 1000 rows, while here in the case of Tableau, it is showing you initial 100 rows only. But suppose if I want to increase this number of rows, yeah, I can also write down here one more zero. I write down here one more zero and press enter or press this button. Now it is having around 1000 rows. Yeah, if I go down here, you see here 1000. Okay, row ID is 1000. But I would say that you should not make it 1000 rows. Keep it only 100. Okay, don't worry that only 100 rows have come over here. No, all the 10,000 rows have come over here. But here for the view purpose, it is showing you only 100 rows. But I've made it to 1000. Now, just now, let me make it to, let's say, I can also write down here one more zero, or let me write down here 11,000. Okay, let's say I want to see 11,000 rows. Let us assume that I don't know how many number of rows are available in my data set. Yeah, so I'm writing here, let's say 11,000 rows. I press enter, and see, when I press enter here, when I press enter, it is showing me here this thing. Yeah, here it is showing me 21 fields and 10,194 rows. What is this fields? Fields means this number of columns. Either we say number of columns or number of fields. So here it is already showing me 21 fields or 21 columns, and this many number of rows are available. So here it will show me the full number of rows, the numbers. But when it is showing me here below, it is showing me initially 100 rows only. So let me make it to here 100. Press enter. Okay. So now it should showing me here 100 rows. Okay, that is fine. So this is the data set. Okay. Now, so as I said that in case of Tableau, the Tableau desktop or Tableau public is not having all the features of data cleaning and data transformation, just like Power BI. Okay. Here we are having a separate tool which is known as Tableau Prep. Let me also show you a quick overview about the Tableau Prep. This is the Tableau Prep builder. Okay. And I think so maybe 2 to 3 months before I had created this kind of data cleaning here. Sample. So this is the Superstore data set you see here. So see here, I was having separate files. Yeah, these were separate files for South region, East region, West region, Central region. Just now in the sample Superstore data set, all the data set, all the files have come together. Okay, but suppose if you are having these kind of situation where you are getting the orders data from various regions, so it will be different files. So I can bring those. Let me see if I can make it bigger for you. No, I don't think so. No, I think so. It is not. Maybe I have to check it. But here you can see that some of the files I brought over here. Okay, I connected with the Tableau Prep. Then I did some cleaning here. Yeah, some fixing some dates, renaming the states. Then I combined all these 4 files into one file. Yeah, so it is known as a data union here. We'll also talk about this data union in our Tableau desktop. And then I did some further cleaning here. I also added the returns table. You see here, there is a separate returns table here. Okay, and that is how I'm doing this data cleaning in the Tableau Prep. So this is a separate tool over here. Yeah. So this is what I wanted to show you here. Another. Yeah, I can also make. Yeah. Now I can make it here bigger. Yeah. Sorry. Okay. So see, this is that cleaning which I have done here. So here you can do many things in the Tableau Prep. But if I'm coming back to this Tableau desktop here, I'll show you some basic data cleaning which can be done over here in the Tableau desktop or Tableau public. So let's say I'm having this customer name over here. Okay, this is the customer name column. Now, first of all, if I click this ABC here, ABC means text data type. If I click this ABC, here I can see all the data types of Tableau. So in the Tableau data type, we are having here decimal number, whole number. Yeah, just click this button, any of this button. Okay. If I click this ABC button, I can see here decimal number, whole number, date and time, date, string. Yeah, here it is identified string. String is text data type. Then spatial, Boolean. Booleans means true and false. Then it is identified as default. Then there are also some geographical fields here, geographical role, image role, blah, blah, blah. Yeah, so here it is identified it as string data type, that is a text data type. Now what I want to do here, I want to create here two separate columns. I want to have one column of first name and one column of last name. I don't want to have a combined column here. So if I want to divide this one column into two columns, or if I want to split this one column into two columns, that is possible here. What I have to do, I have to click this I have to click this drop down here. Okay, click the drop down here, is a drop down button in this customer name column. And then here, when I click on the drop down, I'm having here options like rename, copy values, hide, aliases, create calculated field, create group, split, custom split, and describe. Yeah. Now, before I use this split option, let me show you what is this rename here. Rename, that's very clear that you can rename this thing. But let's say, I'll show you one example here. Rename. Yeah. Now I'm opening this metadata again, metadata table, because I want to explain here that why Tableau has given you these two separate columns here, field name and remote field name, though they are having exactly the same fields, but why these two columns are created here. So now I'll show you one demo. So here in the, let's say we are having here row ID. Okay, the original column name is row ID. Now I want to change it to row number. Instead of row ID, I want to change it to row number. So what I'll do here, just like Tableau, Power BI, we can double click on that field name or column name. So here also I can double click. I double click on the row ID. And now what I do, instead of row ID, I write down here row number. So see, I have double click on this title, row ID, and I have written here row number instead of row ID. Press enter. Press enter. And now here you can see it is now row number. I have changed I have renamed it column. Now see, here it is row number, and now you see the difference here. See, field name, the first field name is shown as row number, but you see the remote field name, it is still row ID. So now you have got that concept that why this Tableau has given you two columns here, because sometimes if I change this column name, then I should be knowing that what was the original column name. Yeah, what was the original column name? So original column name will always be shown in the remote field name column. Yeah, you cannot change this one. You can change this one, but you cannot change this one. Yeah, see, I can double click over here. I can double click on the field name also here, and I can change the name. But I think so here I cannot click here. Yeah, here I cannot click on the remote field name. This will be permanent. Yeah, so that is the advantage that you get for the remote field name, that you don't lose your original column name. Tomorrow, if you want to again go back to your original column name, you can see, okay, it was row ID. So now you can again, I can click on row number. I can type here row ID. Row ID, press enter, and now you see it is row ID, row ID. Okay, so that is the advantage that you get here. Okay. So this was one demo here. Now let us come back to the customer name here. In the customer name, I want to split this customer name into two parts, customer first name and customer last name. So what we do, we click this drop down, and in the drop down, there are two options here, split and custom split. So let us understand what is the difference between split and custom split. First of all, we'll go for split here, split. Yeah, so click on the split button. After clicking on the drop down in the customer name, click on the split button. When you click on the split button, what happens? Nothing happens. You see, you can see that, oh, Samir, nothing has happened here. But now you go to the right hand side. Go on the extreme right of this table. Yeah, you can use this scroll bar, go to the extreme right, and now here you will be able to see these two columns here. Yeah, once you click on the split button in the customer name column, then you go on the extreme right of this table, and here you'll be able to see customer name split 1 and customer name split 2. Yeah, see, these names are given by Tableau. We have not given any name. These names are given by Tableau. Now here if I want to change the title here, because see, customer name split 1, customer name split 2 doesn't look good. What I can do, I can double click over here, double click on the title, and I can write down here customer first name, and I can remove this split 1. I don't like split 1. So see, I've changed the name here, change the title of the column, customer first name. And similarly here, I can double click and I can write down here customer last name, and I can remove this split 2, press enter, and see, now my columns are ready. Yeah, in case of Power BI also we have the split button. So I can divide the splitting. In the split also we are having there 7 options, I think. So in case of Power BI, split by number, and then split by characters and delimiters and all those things. Yeah, there are 7 options which are there in Power BI for the splitting the column. So here, this is how we go for the normal split. Now see what this split has done, that here the splitting has been done when there is a space over here. Yeah, so here we are having this space between the two columns here, sorry, between the two names here. So it has done the splitting yeah, when there is a space here. Okay, so that is how it has used this concept here. So this is the, sorry, these are the 2 separate columns, and remember that the columns that you are creating here, it will be always shown at the end. Okay, so this is customer's first name, customer last name. Let me see. Maybe we can do it later on also. Now, one important thing here. You see that on the top area, you can see this blue line here. Yeah, there is a continuous blue line. Okay. While here, on these 2 columns, there is no blue line on the top. Yeah, here there is a blue line, here there is no blue line. So what does this blue line indicates? So blue line indicates that all these columns are coming from the original data set. They are coming from the original data set. That's why it is indicated by this top blue line. While these 2 columns have been created by us. Okay. So the columns which are created by us, that is what you have also understood in this Power BI, the calculated column. Yeah. So these are your calculated columns. Yeah. Here definitely I have not put up any function here, but still I have created this column on my own. That's why at any point of time, if you are getting confused that which columns are created by me and which columns are coming from the original data set, you can use this blue line here. Blue line means the columns are coming from the original data set. When there is no blue line, it means that these columns are created by us. Whether it is created by splitting or whether it is created by calculated field or calculated column, that's a separate thing. Okay. So that's why these are the 2 columns which are not having that blue line. So this is one splitting. There's a normal split. Now, another example, custom split. Okay, custom split. So suppose here, if you come to this left-hand side area, if you click on this order ID. Now, as I said earlier, that order ID is consisting of 3 parts here. The country ID or country short form, US or CA, the year, and the last 6 digits here. Okay, so there are 3 parts over here. Now, what I want to do, that I want to create one column, yeah, and I want to get only the initial 2 alphabets in that column. Okay, just now in this order ID column, I am having all the 3 parts, but I want to create one column where I want to see only the initial 2 digits, US or CA. Okay, so if I want to extract only one portion of this whole series, what I can do, I can go to this order ID, click the drop down here, and in the drop down, I go to this custom split here. Okay, I click on the custom split, because if I go for split, let us also try what is the split. If I click here split here, yeah, so split I have used. Now let me go to the right hand side here. So see, in the right hand side, what has happened here, it has now created here 3 columns for the order ID. I have used the split option. So order ID split 1, order ID split 2, and order ID split 3. So what it has done, that wherever you are having the dash, at that point the splitting has taken place. Yeah, the splitting has taken place at the dash. Dash is your delimiter, or space is also your delimiter. So it has done the splitting over here. But here we have got how many columns? 3 columns, because there are 2 dash. Now suppose if I don't want to have all the 3 columns, I want to have only one portion, that is this US or CA. What I can do here, I can come to this order ID. I click on the drop down, and in the drop down, I click this custom split. Okay, the custom split. In the custom, when I click on the custom split, I'm having this dialog box. What it says, how should this data be split? Use the separator. So here I have to tell Tableau that what kind of separator I'm having here. So here we are having the separator that is dash. So in the use the separator, I have to put here dash. I have to type here dash. If you are having space, you press space bar. If you are having comma, you press here comma. So use the separator, I put here dash. Type here dash. Now here it says split off. In the split off, if I click the drop down, split off first, last, and all. Now what is this first, last, and all? So see here, how many dash I'm having here? There are 2 dash here. So now I can also tell Tableau that where the splitting should take place, whether the splitting should take place at the first dash or first delimiter, or the last delimiter, or all delimiters. Yeah, the split off is talking about the where do you want to do the splitting, at the first delimiter or last delimiter or all delimiters. So suppose if I go for first, okay, because I want to extract only this US and CA, I go for split off at first delimiter. Then it is asking me, okay, how many columns you require. Okay, now see, if I do the splitting here, yeah, let's say if I do the splitting here, then I'll be having actually 2 columns. One column will contain the USCA, and the other column will contain this another portion. Okay, one column will contain this USCA, and the second column will contain this 2021-103800. Because see, here I have not done the splitting. I am telling the Tableau that please do the splitting at the first delimiter. So split off first, okay, and I want to get only this first column here, okay, because I want to get only this US and CA. So I'll be saying here first one column, okay, split off first and one column. I click on OK button, and when I click on OK button, now let me go to the right hand side, extreme right, and you see now if you go to the extreme right, we are having only one column here, because see, these 3 columns I created by using the simple split option, but this column order ID split 4, this I created only with the custom split, and I said that I want to see only one column. Yeah, if I would have said here 2 columns, then I would have seen here 2 columns. One column will contain USCA, and the second column will contain 2021 dash something. Okay, but I said no, I want to go for only one column, so I can see only one column here. Yeah, so that is how you are using the custom split here. So you can tell Tableau that where do you want to have the splitting, first delimiter or last delimiter or all delimiters, and then finally how many columns you require, whether you want to have 1 column or 2 column or 3 column. Yeah, it all depends upon the column that we require. Okay, so I hope that this is clear. So here you can do these kind of simple data cleaning. You can rename the column names over here. You can do the splitting. Okay, definitely you can also create here calculated field. Calculated field means calculated column. Okay, see here the names are different. In case of Power BI, it is known as calculated column, while here in case of Tableau, it is known as calculated field. Yeah, just the names are different. But we'll be talking about this calculator field when the topic will come up. This group and beans also will be taking at the appropriate time. Yeah. Aliases means different names here. Suppose if I click on aliases, yeah, aliases. Let me do one thing. If I click here row ID and let me write down here row number, and now if I click on drop down and if I click on aliases, yeah, here there's no aliases here. Normally, if see for aliases means I can give some name here. Let's say instead of this ship mode, in the ship mode I'm having the standard class, but sometimes people they also write down something else. Instead of standard class, it will be standard type. Let's say, okay. So if it is standard type instead of yeah, that's a alias for standard class. Then I can see here that what kind of aliases are available here. Just now in this example, there is no aliases. Aliases means different names, okay, for the same thing. What are the different names given? But here there is no aliases, so it is currently blank. Yeah. So we can do this splitting. We can also hide the column here. Okay. So now, first of all, let us connect our sample superstore dataset that we created, that we had seen yesterday. So it's an Excel file, as we know. So we'll be clicking on Microsoft Excel, and then I'll be selecting that file, sample superstore 2024. Okay, click on open. So in the customer name column, as you know, if you want to do the splitting, if we want to have first name and last name, so I can click on this drop down over here in the customer name, and I can click simply the split. Yeah, because I don't want to go for any custom split, I want to go for split only. So I click on split, and once we click on split for the customer name, now we can go on the right hand side, and here we can see those two columns that we have created. Okay, and I also showed you that we can here do the renaming. Then yesterday we also discussed about this blue line. So blue line, I said that if any column is having a blue line on the top, it means that that column is already coming from the original data set. Okay, while these two columns are not having that blue line on the top, so it means that these two columns are created by us. Okay, they are not coming from the original data source. Now, suppose if I want to delete these two columns, yeah, so I can click on this. I can select by pressing the shift button, sorry, control button. So please press the control button, and you can select these two columns if you have created. Otherwise, you can see over here. So press the control button and select these two columns. And now I can click any one of these drop down. And when I click on the drop down, you can see that I'm having here rename option, copy values, hide, and delete. Okay, specifically I'm having this option of delete. Now I will not click here just now delete, but suppose if I click this option, this column, let's say profit column, suppose. Okay, I select the profit column, I click on the drop down. Now in the drop down here in the profit column, I do not see the delete column, delete option here. Yeah, I go for any column here. Suppose if I go for product name, in the product name also, if I click the drop down, I do not see the delete option. I am having only the hide option. Okay, and plus other options are also there, but there is only hide option. There is no delete option here. So what does it mean? It means that whichever the columns are coming from the original data set, those columns cannot be deleted here. Okay, they will stay permanently over here. Definitely you can hide the column. Yeah, suppose if you don't want to see, let's say this category column, suppose. Okay, I don't want to see the category column. So I cannot delete it. I can click on the drop down. I can click on hide. Okay, I click on hide. So see, now my category column is now hidden. Okay, but I cannot permanently delete it. What I can do here, I can delete only these two columns which are created by us. So I'll select this customer name split one. I'll press the control button, and then I'll select the second column. So 2 columns I have selected by pressing the control button, and then I click on one of these drop down and I can click on delete. Okay, so these 2 columns I can delete. I click on delete, and you see that now those 2 columns are gone. Okay, customer name split 1 and customer name split 2, they are gone. Okay, now here I have already hidden the category column. Okay, now if I want to bring that column back, okay, I don't want to hide that column, category column, I want to bring that column back. So what I do, I have to click on this gear icon here. Okay, let me start my marker here. So I can click on this gear icon, and when I click on the gear icon here, you see here it is written show aliases and show hidden fields. Okay, so suppose if I click on this if I click on this gear icon, and if I click on the show hidden fields, if I click it, then I can see here that my category column is now hidden, but I'm still able to see that category column here, you see. And now if I want to unhide this column, category column, I can click on the drop down here, and in the drop down I'm having the option of unhide. Okay, so I click the drop down, I click on unhide, and now you see the category column is now not hidden. Yeah, now it is available here. Okay, so remember this important point, that the columns which are coming from the original data set, original data source, they cannot be permanently deleted from the Tableau. In the Tableau, they can be hidden. If you don't require that field, you can hide that field, but you cannot delete anything. And the same concept is also there in case of Power BI. If you know this thing, in Power BI also, whichever columns are coming from the original data source, I cannot delete it. Yeah, I can hide those columns. Okay, but I cannot delete those columns. Okay, I can, and the columns which are created by me, let's say in Power BI also we are creating the calculated column, so those columns can be deleted by us. Yeah, that is fine, but I cannot delete the original columns. So this is the concept of hide and unhide. Yeah, anytime if you are having any issue, let me know. Now, one more thing here that I want to show you now. See here, we are having the orders table. We have brought the orders table over here. Now, yesterday I showed you the other two tables also, that is the people sheet and the return sheet, or people's table and the returns table. Now, what I want to do, that I want to bring these two tables also over here in this area. Okay. Now, if you remember, yesterday I showed you that there is a common field between the orders table and the people's table. Do you remember the common field between the orders table and the people's table? Yeah, so there was a region column which was common between the orders table and the people's table. And now the second question is coming over here, that what was the common field between the returns table and the orders table? There was also one common field between the returns table and the orders table. So order ID. Okay. So now what we want to do, that we want to bring these two tables also over here, and definitely because there is a common field, so there will be some kind of a join over here. Okay, we'll be connecting one table with another table with the help of a join. So what I'll suggest you, that if you want to create a join, then if you put your pointer over here, okay, when you put your pointer on the orders table, what it says here, logical table equal to orders, and then it says here double click this logical table to see its physical table. Okay, so it is telling us to double click this logical table to see its physical table. So remember that whenever you want to see the concept of join, yeah, between the two tables, then you go for the physical table, or you go to the physical layer. So what you have to do here in this orders table, you have to double click, just double click this orders table. And when you double click the orders table, now this, you see that something has changed here. Yeah, let me delete it again. Yeah, I'll double click this orders table, and now it says here order is made of one table, Okay, now this is a physical table or physical layer, you can say something like that. Now orders is there. Okay, you double click on the orders table, then it will show you like this. Now what I'll do, I will bring this people's table here. Okay, I'll bring the people's table here, and you see when you bring the people's table here, first of all it says here drag table to union. Now I'll also talk about this, what is this union concept, but I don't want to union. You bring this table over here, the people table. Okay, bring it on the right hand side of this orders table, and then you drop it here. Okay, drop it over here. When you drop over here, when you drop the people's table over here on the right hand side of this orders table, you see that now people's table is connected with the orders table like this, and this is your join. Okay, this is your join here. Yeah, so orders table is connected with the people's table. Yeah, and this is a join. Now if I click on this join, yeah, just click on this join, and when you click on the join, you can see that there are these 4 types of join: inner join, left join, right join, and full outer join. By default it is showing you here inner join by default. Okay, so this is the inner join. Inner join means it is taking only the fields or rows. So it is taking only the records or rows which are common between both the tables. Now are you having the concept of or so do you know the concept of these joins? Because these joins also comes in Power BI. Maybe you must have been taught the merging of the tables. Yeah, merging queries. So maybe during the merging queries, these joins must have been discussed. But just I want to check that whether you know this concept of these 4 kind of joins: inner join, left join, right join, full outer join. Yeah, if you already know the concept, then I will not repeat that thing. But if you want, I can also discuss this 4 kind of joins. Yeah, because this concept must have been taught in slide concept. Please discuss. Okay, no problem. So then let me go to this presentation here of Simplilearn. So you will also find this presentation with you. So let me, yeah, here in this presentation, it is showing the same thing what I've discussed. Okay, you see here that in the orders table and the returns table, we have created this join, and by default, it is showing you this inner join. And what is the common field here between the returns table and the orders table? That is the order ID. Yeah, here they have taken first of all the returns table. We took just now people's table, but the concept is same. Yeah, so this join has been created between the orders table and the returns table, and these are those 4 joins that we have also seen in our Tableau. And the common field here is order ID, order ID. Now let us understand these joins here. Okay, so here they have given an example where there are 2 tables here. One is known as your left hand side table, which is having the product sales. So there is a product ID, sales, number of records. Okay, and there is another table which is known as right hand side table, which is having the product profit. So here also you are having product ID, profit, and number of records. Okay, now here, which is the common field between the 2 tables? That is the product ID. Okay, product ID is the common field here. Otherwise, if you see the sales, yeah, definitely the number of records, we cannot keep it over here common field, because this product ID is a common field here. Now let us understand what is this left join. Okay, so what is left join? That in the left join, it will take all the values of the left hand side table, or it will take all the records. I would be very specific here, that it will take all the records of the left hand side table, and from the right hand side table, it will take only those records which are common with the left hand side table. So let me show you the diagram here. See, this is the left hand side, left join here. In the left join, you can see that the left hand side circle is full. Yeah, so when it is full, it means that it is taking all the record of the left hand side table. And if you see the right hand side table or right hand side circle, it is taking only the records which are common between the two tables. So here in this presentation, if I go for the left hand side, if I go for the left join, then it will take all these records of the left hand side table. Yeah. And from the right hand side table, it will take only those records which are common between the two tables. So which are the common product ID? You see here 6, 7, 8, 9, 10. Here also we have 6, 7, 8, 9, 10. So from the right hand side table on, it will only take these 5 records. But from the left hand side table, it will take all these records, whether they are matching or not matching, it doesn't matter. So this is known as left join because we are taking all the record from the left hand side. Yeah. Then comes right join. Right join is just opposite to left join. In the right hand side join, it is taking all the record from the right hand side table, and from the left hand side table, it is only taking those records which are matching with the right hand side table. So here also the records which are matching are 6, 7, 8, 9, 10. Yeah, here also you have 6, 7, 8, 9, 10. But from the right hand side table, it will take all the record, whether they are matching or not matching, it doesn't matter. But from the left hand side table, it will take only those records which are matching with the right hand side table. So this is known as right join. Then comes inner join. What is the inner join here in our table? If you see the inner join here, so inner join means it is taking only the matching record here. Yeah, this is inner join. This is your inner join, matching records. So here in the presentation, if you go for the inner join, then it says here the result of the inner join will include common data present in both data set. So the records which are common between both the tables, only those records will be taken. So here records like product ID 6, 7, 8, 9, 10. Here also we have 6, 7, 8, 9, 10. They are common. So only these 5 records from the left hand side table and 5 records from the right hand side table will be taken, which are common. This is known as inner join. Okay. And the last one is very, very simple, full outer join. Yeah, when you see the diagram also here, if you see the diagram of full outer join, it is both the circles are blue. Yeah, so what does it mean? That it is taking all the record from both the tables, whether they are matching or not matching, it doesn't care. So it is taking all the record from the left hand side table, all the record from the right hand side table, and that is known as full outer join. In case of Power BI, just to give you the difference is here. In case of Power BI, there are 2 more joins, left anti and right anti. Okay, left anti and right anti. There are 2 more joins here. In case of Tableau, we are having only 4. So suppose if I want to tell you what is left anti join. Left anti join means that it will take only those records from the left hand side table which are not matching with the right hand side table. I repeat, in the left NTA, it says here that it will take all the record from the left hand side table which are not matching with the right hand side table. So which are not matching here? The matching records are 11, 12, 13, 14, 15. Yeah, these 5 records are not available on the right hand side. So when I go for left anti join, then it will take only these 5 records, 11, 12, 13, 14, 15. Yeah, only these records will be taken from the left hand side table, but from the right hand side table, it will not take any record. It will not take any record. This is known as left anti. Left anti. And the another concept in Power BI is known as right anti. Right anti is just opposite to left anti. What is right anti? Right anti will take only those records from the right hand side table which are not matching with the left hand side table. So here you can see that these 5 records 1, 2, 3, 4, 5 product ID, these 5 records are not available over here. Yeah, they are not matching. So when you go for right anti, then it will take only, yeah, it is known as right. Sorry for my handwriting. I'm writing by mouse. Right anti. Okay. So what is write NT here? Write NT means it will take those records from the right hand side table which are not matching with the left hand side table, and from the left hand side table it will not take any record. It will take only from the right hand side table, and that is known as write NT. Yeah, this is just for your information. Yeah, but in case of Tableau, we have only these four kind of join: inner join, left join, right join, and full outer join. Okay, good. So what we'll do here, you can decide whether you want to go for inner join or left NT or right NT or full outer join. See, it all depends. See, whatever the join you select here, accordingly, you will see here that the number of rows will increase or decrease. Let me show you here. If I go for inner join, you see here, if I go for inner join, then the number of fields are 23 now. Why there are 23? Because initially out orders table was only having 21 fields, 21 columns, but now it is showing you 23 fields. Why? Because there are two fields which are coming from the people's table. How many columns are there in the people's table? Two columns are there. That is the manager column, and the another column is the region column. See here, you can see if you go on the right hand side here, extreme right hand side, you can see here these are the two columns which are coming from the people's table. You see here the people's table. So regional manager and region bracket people. So you see how it is written here, region bracket people. In the original table, it is not written region bracket people. It is simple written people in the original table, the Excel table. But here it is showing you regional manager and region bracket people. Why region bracket people? Because first of all, you remember that two columns cannot have the same name. Yeah, in the data set, two columns cannot have the same name. So here we are already having the people column. Sorry, region column here. Region column we are having in the orders table. So here in this column, which is coming from the people's table, I cannot write here simply region. It will be written like this only, region bracket people. So it is showing us that this region column is coming from the people's table. Though above also it is written here people, but this is how it is written. Yeah. So two columns are coming from the people's table, and there are already 21 columns from the orders table. That's why you can see that the 23 fields are available. Currently, what is the number of rows? 10,194 rows. Okay. Now suppose if I select here left join. Currently it is inner join. If I click here left join, in the left join also the number of rows are same. Let me click here right join. Right join also same, and full outer will also be same. Okay, so it doesn't matter here. But in other example, you will see further. Let us see with the other thing. So just now what we are doing, we are going, let's say, for the inner join, just for the example purpose. Yeah, you can also close this one. So orders table is now connected with the people's table. Now what we'll do, we will bring this returns table. Okay, this returns table also we bring it over here, and we drop it somewhere over here. Okay, we drop it somewhere over here. So now when you bring the returns table here, returns table is also connected with the orders table. And you see here, as soon as the returns table is connected with the orders table, what kind of join it is creating? It is inner join. Okay, it is inner join. By default, it is inner join. So this is showing you the common field. Yeah, when you click on this Venn diagram, you can see here order ID, order ID. This is the common field between the orders table and the returns table. That's fine. But here, just now, by default, it is inner join. And now you see here the number of rows. See, it has drastically reduced. See, number of fields are 25 now. Why they are 25? Because two fields have come from the returns table. If you go on the right hand side, go on the extreme right, you can see that these two columns, return column and the order ID column, are coming from the returns table. So that's why now we are having total 25 fields. 21 plus 2 plus 2. So 25 fields are there total in now this whole table. Yeah. and the number of rows are very, very low now. 3,226 rows. It is just one third. Initially, how many rows we were having here? 10,100 something. Now, if I want to increase this number of rows, yeah, I can go over here in this returns Venn diagram, this join, and what I'll do, I will go for left join here. Instead of inner join, let me go for left join. Okay, once you click on the left join, then you will see here that the number of rows will increase. So let us click here left join. And you see now when we click on left join, now the number of rows have increased. 12,620 rows. Let us see what happens with the right join. If I click on right join, it is same 3,226. And if I go for full outer also it is 12,620. So I would suggest you, let us go for left join here for the second thing, left join. Okay. So the number of rows have increased. Okay. Instead of 10,000 something, now we are having 12,000 something. Good. So this is how we can do we can join the various tables with this table. See, joins are dependent on what kind of analysis you want to do. Okay. If you say that I don't want to, let's say I want to focus only on those kind of data which are common between both the tables, then you go for the inner join. But if you say, because see this orders table, I feel that this orders table is having all the majority of the records. Okay. So normally it is suggested, normally I'm using the word normally, it is suggested that they go for the left join. Yeah, if your orders table is your fact table, then you go for the left join. So you take all the record, because see, you don't want to miss those records of the fact table. You want to take all the records of the fact table, so you normally you go for the left join. But sometimes it happens that it all depends upon the use case, that if you say that no, I want to focus only on those data set which are common between both the tables, I want to only focus on those order ID which are common between the returns table and the orders table, then you can go for here inner join. Yeah. Now here, if we have done the joining. Okay. Now if I go on the right hand side, extreme right, yeah, you see here that in the returns table, yeah, returns table, initially you will see here null, 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 because there are some records, yeah, there are some order IDs which are not available in the returns table, but they are available in the orders table. I repeat, here if you go to the extreme right, you will see here null, null, null in the returned column in the order ID of the returns table. Why? Because there are some order IDs here which are not available in your returns table, but they are available in your orders table. Now, how it is possible? How it is possible that there are some order IDs which are available in the orders table, but they are not available in the returns table? Items which are, let's say, which are order, definitely, yeah, all orders are not written. Okay, because definitely the customers are happy with the orders, so they would not like to return. Okay, but remember that I saw one story, it was real story, that there was a group of 4 or 5 people. I don't want to name them, I don't want to name the country also, but they had done a big scam of, just they earned the money based on the returning of the product. They actually never returned any product, but they showcased that they had returned the product to XYZ company, and the company had paid the money. Yeah, but actually after 2 to 3 years, the company realized that something was wrong. Okay, and there was a huge amount which they had earned out of that. Yeah, so there are very, very smart people in this world who can do this kind of activity. Okay, that because what happened that, let's say if we are talking about Amazon is they are sending the product, but the returning of the product is taken care of by another company, and sometimes there is no communication between that the third party and this Amazon. So Amazon feel that okay, this person has returned the product, but the third party has not received that product, and Amazon is paying some money, so something like that. So something is happening over there. So many people they have, or some of the people, not many people, but some of the people they have misused this system, and they were earning money out of that. Okay, definitely we should not be going for that, but yeah. So definitely there are products which are not returned. Yeah, not all products are returned. So that's why definitely here we are having this null, null, null. Now, see here, we can see that first of all, we are having all the columns of the orders table. And then we are having these two columns of people's table. And then we are having the two columns of the returns table. Yeah. Now let us click on this gear icon. Yeah, just click on this gear icon again. If you click on the gear icon, yeah, today also I'll show you this aliases, how to create the aliases and what is the use of these aliases. But we have already seen this show hidden fields, yeah, because we had hidden one field and we wanted to unhide. So we already know these hidden fields. Now we focus on this area, sort fields. So if you want to do the sorting here, just here only in this window, if you want to do the sorting of the fields, then by default the sorting is done in the sorting is based on the data source order. Data source, your original source, your Excel file. So whatever the sorting is there in the original source, the same sorting is also over here. Yeah. So that is what we mean by the data source order. But suppose if you want to go for, let's say, ascending, you want to have all the fields in ascending order. So we can click on this A to Z ascending. Okay, I can click here A to Z ascending. And now what happens here, when you click on A to Z ascending, you see here it is starting from category, city, country oblique region, customer ID, customer name, blah, blah, blah. Then comes here order ID. You see here order date, order ID. And then this other order ID is also available over here because they are sorted in ascending order. So this order ID is coming from the orders table and this order ID is coming from the returns table. Yeah, so these two order IDs are together. Then the region column, you see the region column, the two region columns, one from orders table, one from the people's table, they are also shown together. And finally, which is the last column here in the ascending order, subcategory is the last column. Okay, so it starts with category column and it ends with the subcategory column. So this is your, if you click on the gear icon, this is your A to Z ascending. Similarly, if you click on Z to A descending, if you click on Z to A descending, definitely subcategory will be shown first, just reverse, and the category will be shown at the bottom. If you click the gear icon again, then the next option here is A to Z ascending per table. Now, what is the difference between A to Z ascending and A to Z ascending per table? You see, when you go for A to Z ascending, what it will do, if we are having here 3 tables, and whatever the number of columns we are having, all the columns will be sorted together. If you go for A to Z ascending or Z to A descending. But when you want to do the sorting per table, let's say you are having orders table is having 21 columns or 21 fields. You want to do the sorting only of the orders table. Then you want to do the sorting of the people's table. Then you want to do the sorting of the returns table. If you want to do the sorting individually per table, then we can go for this option. Let's say A to Z ascending per table. If I click it. So now here in A to Z ascending per table, it starts with category and it ends over here with subcategory. Okay, so this is your orders table. Then comes the people's table. In the people's table also, first of all, we are having region and then regional manager. And then we are having the returns table. In the returns table also, we are having here order ID and then returned. Yeah, so here it is A to Z ascending per table. And similarly, we can go for Z to A descending per table. But what I'll tell you here, don't change any of these sorting fields. You go with the default one, data source order. I'll tell you why this is not important. Yeah, let's click again here, data source order, this option, data source order. Okay, why this option is not that much important. Yeah, just now, see, when you are focusing only on this area, then you can go with these options, that is fine. But now what we'll do, that once we have connected these three tables with each other, yeah, now let us go to the we go to the visualization area. Okay, so how to go to the visualization area? You can see here at the bottom area, yeah, here on the bottom left corner here, it is written here sheet 1, yeah, below. Okay, and what it says here, go to worksheet. Okay, so now if you want to start creating the visualization, because we have connected the data set here, we have done the joining here. Yeah, now we want to start the data visualization. Yeah, yesterday we saw that there is not that much of data cleaning to be done in this Tableau desktop or Tableau public. The major cleaning can be done in the Tableau prep, but that's a separate tool. So now we want to start with the visualization process. So what we'll do, we will click here below, left hand side bottom area, sheet 1. I click on sheet 1, and when I click on sheet 1, now we are in another window. You see here, this is another window, and in this window you can see that now on the left hand side we are having this data panel. Okay, now just you compare it with Power BI. In case of Power BI, you are having the data panel on the right hand side, while in case of Excel, this Tableau, you are having the data panel on the left hand side. That's the difference. Okay, this is one of the difference. You remember these differences. As I said yesterday, that this can be asked in interview if you are appearing for anything. Yeah. So this is the data panel. Now here there is also some difference here if we compare with Power BI. So in Power BI, what happened, that whatever the fields which we are having, whether it is numerical field or whether it is categorical field or whether it is geographical field, all the fields are shown together in Power BI, and all the fields are shown in ascending order. Yeah, it's always start with the alphabet A and then it ends with Z. Okay, so it shows in the ascending order, but all the different types of fields are shown together. Now here in this Tableau, what happens? You see here, first of all, we are having the orders table. In the orders table, it starts with category, it ends with subcategory. These are all the fields which are coming from the orders table. Then we are having the people's table. So these are the two fields of the people's table that we have already seen. Returns table is also having these two fields. Now you see here, again below, it is showing you again below orders table. Here also there is orders table. Here also below there is orders table. Yeah, and in the orders table here, it is showing you here discount, profit, quantity, and sales. Yeah. So what is doing here in case of Tableau, that all your numerical fields are shown separately here. They are not mixed up. They are not mixed up with these other fields. While in case of Power BI, all the fields are mixed up. But in case of Tableau, these four numerical fields which we are having here, discount, profit, quantity, and sales, yeah, they are shown separately. Suppose if your people's table and the returns table is also having some numerical field, then they will be also shown over here separately. Yeah. So in case of now Tableau, now the concept comes over here, very, very important concept. In case of Tableau, let me show you one concept here. Yeah. So in case of Tableau, we are having two concepts here. One is known as dimensions and another one is known as measures. Okay. So dimensions and measures. So what is this dimension and what is this measure? Yeah. So here it says dimensions contain qualitative values. Just remember the word dimensions means qualitative values and measures means quantitative values. So dimensions contain qualitative values such as names, dates, or geographical data. Yeah. So here in our example, if we see the data set, we are having here city, category, yeah, even customer name, order date, order ID, postal code. These are all qualitative data. Okay. Product ID, yes, you can see here that product ID, but our product ID is combination of some text, some year, and some numbers. Okay. But if I focus on, let's say, category, so we saw yesterday the three categories: office supplies, technology, and furniture. So whenever you are having these different categories, okay, or different customer names will be different, okay, the ship mode is different. There are various kind of ship mode like same day, first class, second class, yeah, likewise. Then ship dates are also different. So whenever you are having these kind of fields, they are known as dimensions. They are known as dimensions. And if we are talking about the numerical field, let's say these are your four numerical field: discount, profit, quantity, and sales. They are known as measures. Okay, so you have to remember these two words here. Here, that is dimensions and measures. What are measures? Measures contain numeric quantitative values that you can measure. Measures are aggregated by default. Aggregated by default means we will see further that if I take the sales value, if I take the sales field, it will be doing the summation. Yeah, in case of Power BI also you saw that when we are taking the any numerical field, it will by default do the aggregation, sum. Okay, it will sum all the sales, it will sum all the discount, it will sum all the profit. That is the default characteristic of a numerical value. So here also our measures, when we use the measure in the visualization, it will do the aggregation. Yeah, we'll see today only. Yeah. What is dimension? Dimension means, you remember the example of dates, names, categories, yeah, geographical data like city, yeah, country. These are all the examples of dimensions. Okay. Now, if you focus on this right hand side area, you see that this area, okay, these are all your dimensions. Okay. And if you see the color of this data type or this icon here, the color of these icons are blue color. Yeah, they are all blue color here, the icons I'm talking about. While if you focus on this area, okay, you see the color of this data type or color of this icon, they are green color. So what is this blue color and what is this green color here? Okay, so now we'll discuss this point here. Yeah, because they are identified separately here. Okay, so if we want to understand this blue color and green color, then let us come back to this area. Yeah, this is the, if you want to have this article, I can put it over here in the chat panel. Yeah, so that you can refer it later on. So here it says blue versus green fields. Yeah, that is what we want to discuss now. Tableau represents data differently in the view depending on whether the field is discrete or continuous. Now there are two more words here. Initially we saw these dimensions and measures. So dimension is having qualitative value and measures is having quantitative value. Okay. While here, continuous and discrete, dimension and measures, yeah, they are very clear. But now comes here continuous and discrete. These two words also, that also you have to remember. What is continuous? Continuous means, here it says continuous means forming an unbroken whole without interruption. These fields are colored green. When a continuous field is put on the rows or column shelf, an axis is created in the view. Yeah, first of all, let us read this line and then I'll explain. Discrete. Discrete means individually separate and distinct. These fields are colored blue. When a discrete field is put on the rows or column shelf, a header is created in the view. So in simple words, if I want to explain you what is discrete and what is continuous, discrete means you are talking about the customer name, let's say. Okay, so customer names will be separate. It is discrete. Okay, if we talk about categories, subcategories, ship mode, they are all discrete. Yeah, one category will be totally different from the other category, so that is known as discrete. While continuous, example will be, let's say, temperature. Okay, now example is temperature. Temperature will be, let's say, it will be 10.1, 10.2, 10.3, 10.4, 10.5, yeah, and so on. Then it will be 11.1, 11.2, 11.0. So it's a continuous value. If we talk about pressure, whatever the value of the pressure will be there, that will be also continuous value. Okay, if I'm talking about the marks, also marks of the marks in the exam, they are also continuous. Okay, so normally you remember like this, that whichever fields which are having numbers, they are by default continuous. Whichever fields are having numbers, they are by default known as continuous field. So normally all your measures are by default continuous, because measures are containing the numerical value. So by default measures will be continuous. And by default dimensions, yeah, dimensions will be by default discrete, because dimensions, I gave you that example here, names, dates, geographical data, yeah, they are all separate from each other. So they are by default discrete. Okay, so remember like this, that dimensions are by default discrete, measures are by default continuous. Okay, by default you use that, you remember that word, by default. But here we can see that discrete dimension and continuous dimension. Now see, I said that dimensions are by default discrete, but here it is also showing you an example where dimensions are also continuous. Okay, so I can convert, remember one sentence, I'll also show you practically that dimensions which are discrete by default, I can also make it continuous. See here you can see this order date. What is order date? Date is a discrete value. It's a dimension. So normally the date will be discrete because it's a dimension. But I can also convert the same date into a continuous dimension. Yeah, but I'll show you this thing practically in the Tableau. Now measures are by default continuous. So here we can see sum of profit. This is a continuous measure. But a measure can also be discrete. A measure can also be converted into discrete value. So that also we'll say practically. Okay. So a dimension will be by default discrete, but a dimension can also be converted from discrete to continuous. And when the dimension is converted from discrete to continuous, what is the discrete dimension? Discrete dimension is always shown in blue color. But as soon as you convert the dimension into continuous value, you see here the color is now green color. Okay. And when the measure is continuous, by default the measure color will be green color. But when you convert that measure from continuous to discrete, the color will change from green color to blue color. So I would say that I can think that it will not be so easy to understand this concept, but once we'll go for the practical part now, then you'll understand this concept. Okay, but at least you remember these 4 words: dimensions, measures, discrete, and continuous. Yeah, just take these words here. Okay, discrete means they are separate. Okay, while continuous means it's a continuous value. Okay, and as I said that dimensions are by default discrete and measures are by default continuous, but a dimension can also be converted to continuous value, and a measure can also be converted into discrete value. And these are the examples over here. Yeah, but you can check this link also, which I've shared over here. Yeah. Okay. Good. So now let us come back over here with this theory part. So here you can see that all these dimensions, yeah, which are by default discrete, so they are shown in blue color and they are shown separately here, while the measures are shown separately, and measures are by default continuous, so they are shown in green color. Okay, so this is just the difference between the Power BI and Tableau. Yeah. Now here we can see that this is your canvas. Okay, in this canvas we'll be creating the visualization. Then above here we are having these two blocks on the top area. These two blocks are columns and rows. Okay, so columns means you can say x-axis and rows will be your y-axis. Yeah, normally in case of Power BI we use don't use columns and rows, we use their x-axis and y-axis. Okay, so you can understand that these columns is x-axis and rows is y-axis. Then we have here these blocks are there. We will see also see one by one pages. Then we are having filter block or filter panel. Then we are having this marks card. Okay, these are the various panels that we are having here. We'll be using it one by one. And then if you click this one here on the top right corner, it is written here, show me. Yeah, here, top right corner, show me. If you click this show me, when you click the show me here, then here you are able to see the standard visualizations. Okay. When you see here show me, if you click on show me, you can see here this is your text table. You see when I put my pointer here on the first visualization, below it is showing me that name. So when I put over here, it says text table, one or more dimensions, one or more measures. So what it is showing here, it is showing you the name of the chart, and plus it is also showing you that how many fields you require and what kind of fields you require to create that measure or sorry, to create that chart. So suppose if I put my pointer here on this first chart, it says text table. For creating a text table, you require minimum one dimension, one measure, minimum. Okay, that is what it is saying. If you are having more, it is fine. But minimum for text table, you require one dimension and one measure. Then this is your heat map. Heat map also require one or more dimensions and one or two measures. Likewise, this is highlight table. So we'll create one by one all these visualizations today or maybe in the next session also. So we'll see these various types of visualization here. Okay, so this is known as show me. And if you don't want to see the show me, you have to click this show me again, click on the title show me, and it will get collapsed. Okay, so these are the things. Now what we'll do, let us create our first visualization. Yeah, so here on the left hand side we are having this category. So what I'll do, that I want to see the total sales of various categories, and I want to know that which category is having the highest sales, which category is having the lowest sales. Yeah, so I want to focus on the category. So what we have to do, if we want to create a chart, what we do, we drag this category. Now see, when you drag the category here, you see here, just focus on this line. Sorry, this one. Okay, just focus over here. Let me draw it again. Okay, see, you can see that there is a thin line over here. So what is this thin line here? This thin line is bifurcating the dimensions from the measures. Yeah, because below this thin line, all these are measures, and above the thin line, these are all the dimensions. Yeah. Now, before I forget one thing, you see here that in this in the dimension area, you can see these measure names. Okay, there is one dimension which is known as measure names, and there are these four measures. You see these 4 measures. What is written here? Latitude generated, longitude generated, orders, bracket count, and measure values. Now see these 5 things which we are having here, 5 fields which are shown over here, they are not in our original data set. Yeah, you have never seen these kind of fields in your original data set. Now see, if you want to go to the original data set, what you have to do? If you want to see that table, sorry, missed your table. Yeah, just now what we connected that returns table with the orders table and the people's table with the orders table. Yeah, that join. If you want to go back to that page, what you have to do? You have to click this one. Just click this data source. Okay, bottom right, bottom left corner here, you click on the data source. And when you click on the data source, you are back over here. Okay, I can also double click this orders table. And when I double click the orders table, I can see this join. Okay, so just click on this data source when you are in the sheet. Yeah. So here you can see that in the data source, when I see all these fields here, I do not see here latitude, longitude, measure names, measure values. We are not having these kind of columns here. There are no columns like this in our data set. But if I go back to this sheet 1, yeah, just click on sheet 1, and now here these 5 fields are available. So remember that these 5 fields are generated by Tableau automatically. Whenever you are connecting any data set to Tableau, Tableau will automatically generate these 5 fields here. Measure names, latitude, longitude, orders, bracket count, and measure values. And we do not have here any control. Okay, I cannot stop this process. One more thing, that this longitude and latitude, these 2 fields, we will only see in that data set which is having at least one geographical field. I repeat my sentence, that this latitude and longitude field will be automatically generated by Tableau only when your original data set is having at least one geographical field. So here in our case, what are the geographical field? You see here, city, it is having a globe icon. Country is having a globe icon. Postal code is also having globe icon. And the state oblique province is also having globe icon. So here in our case, we are having four geographical field. So definitely these latitude and longitude fields will be generated automatically by Tableau. But let us assume that in our data set, we don't have any of these geographical field. Let us assume like that. So when you don't have any of the geographical field in your original data set, then Tableau will never create these 2 fields, latitude and longitude. Yeah, then Tableau will create only 3 fields, measure names, count, and measure values. That's all. But if your data set is containing at least one geographical field, it can be country, region, city. Yeah. Normally region is not counted as geographical field, but country, state, city, postal code. Yeah. So these are all the geographical fields. So if your data set is containing one geographical field, minimum one geographical field, then automatically this latitude and longitude columns will be generated by Tableau. You don't have any control over here. Clear? And also these measure names and measure values and these orders count, they are also having its importance. Yeah, these 3 fields, measure names, count, and measure value, they are not just generated just for fun by Tableau. It is having its own importance. So that also we'll see further. Clear? So now let us create our first visualization. So as I said earlier, that we'll be dragging this category, and you see when you are dragging the category here, I was talking about this line here. Yeah, when I drag this field, yeah, just focus on this area. So what it is showing me here? It is showing me here the 2 words, dimensions and measures, below that line. Yeah, near that line we can see the dimension. I remember that in the older versions of Tableau, yeah, because I'm also using this Tableau tool for last 7 or 8 years. I learned this Tableau when I was doing my master's in data science from Bologna University in Italy. Yeah, so there this Tableau was part of our course. So there I learned this Tableau. So during those days, we were having or say the version that we were having in those days. Here in those days, in those versions, it was clearly mentioned here on the top area dimension, and here it was below mentioned measure. But now they are not mentioning over like this. Yeah, so whenever I drag the field, you see here below that line, yeah, just focus on this one area. Yeah, now it is not showing me, but yeah, again I drag it, so now it is below, it is showing me dimension and measure. So I drag this category, I put it here in the columns area. Yeah, I drop it over here in the columns area. So see now this category, when it's dropped over here, I can see these three categories. Okay, furniture, office supplies, and technology. Now what I require here in the row section, I require a numerical field, minimum one numerical field in the row section. So what I do, I click here, I select here sales. Let us select here sales, and I drop it over here in the row section. So see, when I drag the sales and when I put it over here in the row section, what it does here, it does the aggregation. It is doing the aggregation. Yeah, because it's a measure. Measure is always doing the aggregation. It's a continuous value. See, measure are by default continuous. So they are shown in green color. This is a capsule. Yeah. And the category is a discrete value. So it is shown in blue color. And now you can see, as soon as you drag the sales here, yeah, it is doing the sum of sales by default. And now I can see the chart. This is a column chart. Yeah, this is a simple column chart. Now see here, this column chart is ready, but you see that here we are having lot of blank space. Yeah, there is a lot of blank space here. Now remember one thing, yesterday I told you that in the case of Power BI, as you know, that in Power BI on one page, I can create many visualizations. Yeah. In the Power BI desktop I'm talking about, on one particular page, I can create 5 visualizations. I can create 10 visualizations also. In case of Tableau, here you see the name below, what is written here, sheet 1. So in Tableau, we are having various sheets, sheet 1, sheet 2, sheet 3, sheet 4, just like Excel. In Tableau, in one sheet, I can create only one visualization. Here in this sheet, yeah, you can, you will suggest me that, okay, Samir, here also we can create another visualization. No, it is not possible. Yeah, I cannot create here another visualization in this one sheet because this visualization is already created by me. So this is the difference here between the Tableau and Power BI. In Tableau, in one page or one sheet, I can create only one visualization. So now what we have to do, we have to utilize this empty space because it doesn't look good. So to utilize this empty space, what we can do, we can click on this drop down here. You see on the top area, this drop down. Yeah, if I click on this drop down, I can see here 4 options: standard, fit width, fit height, and entire view. Click this drop down. So by default, it is standard. By default, it is standard. Now, if I click on fit width, yeah, just click on fit width. So what happens when you click on this fit width, it is expanding horizontally. Okay, so now this is looking good that it has occupied the whole area. So this is fit width. What is fit height? Fit height means it will go vertically. It will expand vertically. But what is my suggestion to all of you, that sometimes what happens that if we are using fit width, so it will expand vertically, it will expand horizontally, but it will not expand vertically. If I click on fit height, it will expand vertically, but it will not expand horizontally. So what is my suggestion to everybody, that don't use your brain, simply click on entire view. What is entire view? When I click on entire view will expand horizontally also, it will expand vertically also. Yeah, in some of the scenarios you will see this thing, that when I click on fit width, it will expand horizontally, but below you will be having some space. So it will not expand vertically. It will expand horizontally only if we go for fit width. So what I do always when I am having here standard, instead of standard, I simply select here entire view. So it will expand in both the direction, vertically and horizontally. Yeah. So every time I'll be telling you, please make it entire view. So you have to come over here to this drop down and you have to click this entire view. And now it is done. Okay. Good. So this is what is your, yeah, here we have created the whole page. Okay. Whole sheet. Now, if you see the sorting here, see how the sorting of this column is done. It is written here furniture. The first column, first block is of first column is of furniture, then office supplies, and then technology. So here the sorting is done. How the sorting is done? The sorting is done in the ascending order of the category. So first of all, it starts with furniture F, then O, and then T. So sorting is done. But now what I want to do, I want to do the sorting of these columns based on the sales. I want to see the category which is having the highest sales. I want to see it first, and the category which is having the lowest sales, I want to see at the last. Okay, so I want to sort these columns in the descending order based on the sales. I don't want to do the sorting based on the name of the category. I want to do the sorting of these columns based on the sales, and that too I want to do it in the descending order based on the sales value. So how we can do the sorting? So say sorting can be done in various ways. So I'll show you one of the way here. You see here, when I put my pointer on the sales column, yeah, the sales title, there is one small button over here above the sales word. Yeah, can you see this button here? Yeah. So we have to click this button. This is the sorting button. Just put your pointer above the sales, put your pointer on the sales, and then you will see this button. See, as such, I'll not see this button, but when I put my pointer on the sales, this button will appear. I click on this button. When I click on this button for the first time, you see the sorting is done now. The sorting is based on the sales. Yeah, we can see that technology is having the highest sales, followed by furniture, and then followed by office supplies. If I want to do the sorting in the ascending order, based on the sales, I have to click this same button again. Yeah, this button again, I click it, and now you can see it is doing the sorting in the ascending order based on the sales. And again, if I click this same button third time, okay, third time I click it, then now it is doing the sorting, but it is now doing the sorting based on the category name. See, again, we are having furniture, office supplies, and technology. Okay. So this button is used for sorting. When I click the button for the first time, it is doing the descending sorting based on the numerical value. When I'm clicking the button for the second time, it is doing the ascending sorting based on the numerical value. And when I'm clicking this button for the third time, it is doing the sorting based on this category. Okay, so this is one method here by clicking this button, sorting. There are two more buttons here. You see on the top area, these two buttons are available. These two buttons are also done for sorting. So see, the first button is ascending. Okay, this is for the ascending sorting, and the second button is doing the descending sorting. Based on what? Based on the numerical value. Whichever numerical value you use here, whether it is sales or profit or whatever, yeah, it will be. You can also use these two buttons. So if I click this first button here on the top area, this is the ascending sorting based on the sales. And if I click the second button here, it is doing the descending sorting. See, here I'm not having the third button for the sorting based on the category. I'm not having here third button. I'm having only two buttons, either ascending or descending. Yeah. So this is also the area where you can do the sorting. Clear? And there are also one or two more methods here for sorting that I'll be showing you as that topic comes up over here. Yeah, if you want to give here the sheet name, let's say here it is written below sheet 1. Now, if I want to give a proper sheet name, yeah, because sheet 1 doesn't look good. So here we can also double click, yeah, below where it is written sheet 1, you can double click and you can write down here column chart. Okay, type here column chart here. So yeah, this is the column chart. And what we'll do now, we will save this file because the same file will be using it today also and then in the other sessions also. So now we will save this file. Okay. So how to save the file? We'll go to, as usual, file. Okay, file. And in the file, we are having here save and save as. We'll go for save as here. Okay. And now I'll request you to save this file in a proper folder. So you can create a Tableau, let's say Tableau report folder or something like this. And then you can, yeah, you can save this file. But let me show you one important thing here when you're saving the file. Just hold on. So see, I'll save it in, let's say, desktop folder. Okay, in the desktop, I'll click on this new folder, and here I'll be creating a folder which is known as Simplilearn Tableau batch. Yeah, December 2024, suppose. Okay, so I'm creating one folder here. Accordingly, you can create your own folder. And now I'll be saving this file. Now, what I'll do here, I will save this file as sample superstore data set. Yeah, I can give, yeah, you can give your own name also over here. So file name I'm giving here, I'll give here day day 2. Okay, because today is day 2. So day 2 sample superstore data set or sample superstore report. Okay, so you can give like this also. So day 2 sample superstore report. And now what I'll do here, you see that here it is written as save as type. Now in the save as type, if I click the drop down here in the save as type, then there are two options here. Tableau workbook, which is having the short form .twb, and the another one is known as Tableau package workbook, which is known as .twbx. Now let us understand what is the difference between .tw and .twbx. See, suppose if I save this file as .twb, which is known as Tableau workbook. Suppose, okay, I'm not clicking the save button. Let us assume that I'm saving this file as .twb. So what happens here that if I save this file, now suppose if I want to share this file with you, okay, so I can definitely share this file with you. Now, if you if you download this .tw file into your laptop, and when you open this file in your laptop, what will happen that it will show you one message that you have to connect the data set with this .twb file. So remember that when you are creating a .twb file, the data set which we are using over here, which I'm using over here, that is the sample superstore data set, the data set is not getting connected with this .twb file. Okay. When you open this file in your laptop, my file in your laptop, then what you have to do, you have to again reconnect that sample superstore data set, that's the Excel file, you have to reconnect with my file, with my this Tableau file. Yeah, so that is what we mean by .twb. The another option over here is Tableau package workbook, which is known as .twbx. What is this .twbx? When I save this file as .twbx, then the data set which I'm using over here, the sample superstore data set, that also get attached with this Tableau file. So if I send you this .twbx file, and when you download it into your laptop, and when you open my file, you'll not have any problem. Yeah, you don't have to connect the data set with this file because the data set is already there attached with this file. So normally I would suggest you to save this any of your Tableau file as .twbx. Okay. So whenever I'm teaching this subject to the university students also, and when I'm conducting their exam, definitely in the exam I'll be asking them the practical question. So I always specifically mention that please save this your Tableau file with the extension .twbx. Okay, definitely I'll be also having the data set, but for what happens that every time if there are 60 students in a class, every time I have to connect the data set and then only I can see the visualization here. Otherwise it will be difficult for me to see the visualization. So I always tell my university students to save the file as .twbx, so that as soon as I open their file, as soon as I download their file and I open their file, I can see all the visualization. Then I don't have to connect any data set. Okay, so I'll also request here all of you to save this file as .twbx. Okay, so in the .twb, no data set is connected. In the .twbx, the data is also connected with your Tableau file or Tableau report. Okay, so I'm saving it as .twbx and I've given this name, Day 2 Sample Superstore Report. I click on Save button and now it is saved. Okay, now it is saved. So this is how we are saving this file. Now I'll also show you very quickly here. If I go to this Tableau public, okay, just focus over here. Is this Tableau public? No, this is not Tableau public. Just hold on. Yeah, let me close this file. Yeah, I'll also open this Tableau public. Okay, you don't have to open it, just focus over here. Okay, so this is the Tableau public. Okay, just for your knowledge purpose here, in the Tableau public here. Yeah, just focus over here. I'm connecting that data set. Okay, I'm connecting that sample superstore data set here, and now here I'm dragging that order sheet. Okay, I'm not dragging here people sheet and return sheet. I'm dragging here the order sheet. Now I'm going to the sheet 1. Okay, and in the sheet 1 I'm creating the same chart in the Tableau public. So category I'm putting over here in the column section, sales I'm putting over here in the row section. I'm making this, instead of standard, I'm making it entire view, and I'm doing the sorting. Okay, I'm doing the descending sorting. So see, this is my Tableau public. Okay, just yeah. So now in the Tableau public also, if I want to save this file, I can go to file, and in the file I'm having here options like save to Tableau public, then save as, and save to Tableau public as. Now see here, there are 4 options in the Tableau public. Initially, I would say that almost like 6 months before or 1 year before, here in the Tableau public, I was having only 2 options to save the file. What were the 2 options? Save to Tableau public and save to Tableau public as. Okay, there was no save and save as option in the Tableau public here. So what was the initial problem with the Tableau public? That if I want to save this file, let's say I want to save this file on my laptop, then I could not save that file on my laptop with the Tableau public. I can save this file on the Tableau cloud platform. Tableau is having one cloud platform which is known as Tableau public. That name is also known as Tableau public. So if I'm using Tableau public, I could not save over here in my laptop. That was the earlier version, not now. Okay, now I can save this file. Yeah, if I click over here on save as, I can save it in my laptop, on my desktop here. Okay, this is not possible. So this is a good thing. But earlier, I could save only in this Tableau public. So suppose if I click here, save to Tableau public as, if I click over here, then what it says here, Tableau public sign in. Okay, so I have to now sign in here. Now see, normally if because you have not created any account, or if you have created the account, then here you have to write down your email ID. So let me write down here my email ID here, which I've used here. Okay, this is one of my university email ID. Okay, so I'm logging over here. I hope it should work. Yes, now it is working. So see, now I have logged in, and normally when you are not logged in, and you can create your own account here in the Tableau public, and then you enter into the Tableau public, the cloud-based platform, and now here it is saying save workbook to Tableau public. Publishing this workbook will make it available on the Tableau public website. Now see, there are two things here. One is known as Tableau public, which is a tool that what I'm currently using over here, and there is another concept known as Tableau public website. So just now what I'm doing, I'm saving this file which I've created in Tableau public, and I'm putting it on the Tableau public website. Okay, make sure it doesn't contain private or confidential information. Now see, this line is very, very important. Make sure it doesn't contain private or confidential information. Now why this line is coming over here, that also I'll now tell you. So here it is asking me workbook title. So by default it is book 1. I don't want to save it as book 1. I'll write down here as day 2 sample superstore report. Okay, I'm giving the same name here, day 2 sample superstore report, and now I'm clicking on save button here. What I'm doing here, I'm saving the file into the Tableau public website. So I click on the save button here, and now it is saving. Okay, now I'll show you that website. Okay, see, this is that website here. I'm bringing this website here. So see, now this is my browser, and what is the initial this URL over here? It is public.tableau.com. Okay, in case of Power BI, you know that concept, that is Power BI services. Okay, so normally we publish that our report into the Power BI services. Now this is also a cloud-based platform from Tableau, and the initial URL is written public.tableau.com. Okay, now here this is the report which I published over here. Okay, so here it is written day 2 sample superstore report by Samir Wadia. Okay, I can also create here my profile. Okay, so see, here I can create my own profile. I can put my photo over here. Yeah, now if you remember that when I was saving this file into the Tableau public website, it was telling me that please do not use the private and confidential information. Okay, why it was telling me this? Because now this URL which is there, yeah, this is now public. So anyone can see this particular report. Anyone in this world can see my report. Yeah, so this Tableau public website is a free website. Okay, I'm not paying anything for this website, and plus anyone can see my report. And also I can see the other person's report also. Suppose if you search my name in this Tableau public website, you will get my name. You'll come to my account, and then you can see all the reports which I've created over here. Okay, and I can also see your report if you are published on the Tableau public website. So that's why, because this platform is open platform, that's why I would strongly suggest you, do not use your company data and do not publish your company data report into this Tableau public website. Okay, remember this thing, because your company data are very, very sensitive, and if you put it over here, anyone can see your report. Okay, so remember this thing. Only you should use the dummy data. Yeah, if you are using the sample superstore data or this global superstore data, what I've shared with you, or any other dummy data, then go for this thing. Okay, you use only the dummy data and you can put your report over here. Now, what is the advantage of this Tableau public website? So see, yesterday I told you that if you are writing in your CV that, okay, I have completed my Power BI course, I have completed the Tableau course, that will not really help you. What you have to do, you have to do your more marketing. That is what I mentioned yesterday. Now, how you can do the marketing that you really know about this Tableau? What I used to do, yeah, before 7 years back, yeah, when I was applying to various companies and their jobs. So what I used to do that in my CV, where I was writing that word Tableau in my CV, that okay, these are my skills, I was giving a link on my CV. Okay, so anybody will open that web, where my soft copy of my CV, yeah, and if they click on the Tableau word, then they will come over here to this my profile, and then they can see all my various reports which I've created over here. So remember that if you are planning to change your job, or if you want to come to this data analytics area, yeah, and if you want to showcase your work to the recruiter, then please create a proper this Tableau public profile. Okay, so here you should be having your photo, you should be writing something, yeah, in this edit profile. If I click it, yeah, here the LinkedIn link is there, website if you are having your own website, yeah, if you are currently working in some organization, write on your title here, organization, and here you can write down your bio. Here it says introduce yourself to the community, use hashtags about your interest to make it easy for others to find you. So you have to create a proper profile over here, okay, with your photo and everything. Don't keep this photo blank, okay, it will not do good. Put your proper professional photo over here, and then what you can do here, that you can share this link. Yeah, either you can do one thing, you can if you don't want to create a link in your CV, you can, when you are let's say sharing your CV with the recruiter, you can also say that, okay, please find my data visualization work in Power BI and Tableau by clicking the following link. So in Power BI also you are having the Power BI services, okay, so you can use that Power BI service link and you can paste it in your email, and you can also paste this link here, this URL. So what happens that when any recruiter wants to see your work, yeah, they will click that link, and then they will come over here, and then they will see the visualizations, and they will see the report, and then during the interview they will ask, okay, can you explain me this report, what was the data set, how did you create this report? Definitely this you'll not be creating a very simple visualization, you'll be creating a little bit complex also. So they will directly ask questions from your own report. Now see, you have already created this report, so you are very confident, yeah. So maybe it is possible that your interview will be focusing only on this thing. Normally in this data analytics area, yeah, they'll be asking you the technical questions, there'll be technical round. So create a proper profile over here. Yeah, this is the platform where you can showcase your work, and this is how the recruiter will get some confidence that yes, you have created so and so visualization. So after, once your project is also over, after this course is over, once your project is over, please publish your report or your project over here. Yeah, and then later on, whenever you are creating, you are working with some different data set and you are creating some report, please publish over here in the Tableau public profile, in the Tableau public website. Yeah, this is the platform for doing marketing. Okay, and here I can also search any other person here. Suppose if I search here, if I click on the search button, I'll show you one of the expert. Yeah, his name should come here. Yeah, this is one of the expert, Kirill Eremenko. Okay, so I can search over here in the Tableau public website, and I can go to this person website or web page, Kirill Eremenko. If I click it, so see, this is one of the report which has been created by this person. These are, see, these are the various tabs over here. Yeah, regional orders, office supplies, unemployment. Yeah, but actually this is not the person who is created. Kirill. Okay, Kirill is having a different website, but a web page here. But you can see this thing. Okay, Then there is also one Indian, which I like his work. His name is, you see here, someone has created a resume in the Tableau. Yeah, can you see this thing? Pawan Talware. Yeah, let us see here his website. His link over here. And you see, he has created all these things in Tableau. This is not created in Word. Okay. So you can also do this thing. I'm not saying that immediately you should start with this thing, but there are creative people in this world who can also do this kind of thing. Yeah, this is a great thing. Yeah, even I have to also think twice that how he has created, but definitely it is possible. So you can also create this kind of resume. Even in case of Power BI, also you can create a resume in Power BI like this. Yeah. So here you can see the work of other people, and you can get a lot of motivation. And you can also make this favorite. If you like this resume, I can also make it favorite here. Yeah, this star, I can click it, and when I go to this my profile, yeah, when I go to the profile, I can click on my favorite, and you can see that now that person's resume is now favorite because I like this work. Okay. Then you can also follow people. You see here it is written following and followers. Now I'm using here another account. This is not my real account, but in my another account, some people are following me, and I'm also following other people. Those who are experts in Tableau, I'm following them. Yeah. So here I can follow other people, and if I like this person's work, I can also follow him. Yeah. So this kind of activity is there here in the Tableau public website. I hope that I have made you. Can you please repeat again the saving in public version once again? Yeah. So public here, if I go to this Tableau public, I have to go to file and I have to click this option, save to Tableau public as. Save to Tableau public as. If I click it, and then it will, if you are not logged in to Tableau public, then you have to log in with your email ID and password. If you have not created an account, you have to create an account. Then you log in, and then here you have to write down your workbook title, means workbook name. You have to give your proper title here to the workbook, and then you can click on the save button. And as soon as you click on the save button, you will open up this URL. Okay, it will open up the browser, and it will take you to the Tableau public website. Yeah, I hope that it is clear. Okay, so this is a great platform, but as I again I'll repeat that sentence, that please do not use your company data, your sensitive company data, and you please, yeah, you can use it. Means you can use your company data, put it into Tableau, but keep that Tableau file within your laptop only. Don't put it into the Tableau public website. This is very, very dangerous. Okay. So this is a great platform. You can check this thing later on. Yeah, and please create a proper profile here. Yeah, if you want to, let's say, send it to your recruiter, yeah, you should be writing something in your bio, put some proper photo over here. Yeah, likewise. So this is the Tableau public tool. From Tableau public, we can say publish the report to the Tableau public website. Now in this Tableau desktop also, see, now I'm in the Tableau desktop. Now in the Tableau desktop, if I click on file, in the file I'm having only these two options, save and save as. So suppose if I have created a report in the Tableau desktop, not in the Tableau public, I've created the report in Tableau desktop, and if I want to save it onto the Tableau public website, then what should I do? So what I have to do here, I have to go to this server. See, there is one tab here known as server. Yeah, after format, there is a server. In the server, I can go to here, the last option, Tableau public. And in the Tableau public, I'm having that same option, save to Tableau public and save to Tableau public as. Yeah, so you should not worry that, oh, I'm using Tableau desktop. Now, how should I save this file and how should I put it into the Tableau public website? So you have to come to the server here, server tab, go at the bottom, last option, Tableau public. And when you come to the Tableau public, you can click here, save to Tableau public as. If I click it, Yeah, it will give me the, I have to sign in here. Okay, I have to sign in here, and then I have to publish this report to the Tableau public website. Okay. So remember that when you are applying to various jobs related to this data analytics, then please try to create at least 5 to 6 reports. Yeah, you create 5 to 6 reports in Power BI, you create the 5 to 6 reports in Tableau. Maybe you can use the same data set or different data set also, that is fine. Yeah. And I would like to show you one website here. Just hold on. There is one website where you can get many data set, because sometimes I'm getting these kind of question that, okay, Samir, if I want to work with different data set, where can I find the data set? Okay, so there is definitely, you can go to Kaggle. Yeah. Kaggle, there are a lot of website here. Then there is one website where I saw a lot of data set. That is, the website name is Maven Analytics. Okay, Maven Analytics, they are having their own courses, but I would not tell you to enroll for those courses. But here, if I go to this website, just type, yeah, just write down this link, this name of the website, that is Maven Analytics. And if I go to their website here, yeah, they have created a lot of courses here, but I will not go for it. But maybe discover. Yeah, here. You see, if I click on this discover, and if I click on this resources, in the resources I'm having here data playground. Okay. Here it says free practice data sets handpicked by Maven instructors. If I click on resources, if I click on data playground, then here, you see here, these are the various data sets. Okay. So these are great. And I think so there are many. Yeah. So see how many are there? 1, 2, 3, 4, 5. So 5 data sets per page. And I think so there are total 13. So 13 5s are 65. Around 64, 65 data sets are there. Okay. And they are of different variations. So you can use this, and this is available free of cost. Okay. You click on this download button. Let's say if I want to go for this wine tasting data set, they will see that, okay, how many records are there, how many number of fields are there. Yeah. In which type it is available. It is in CSV format. If I click on this download, it will show me here CSV. And if I click on CSV, and then my downloading has started. Okay, so I'm not paying anything for this thing. So this is a recently I saw this website. Miss, I know this this Maven Analytics, but I came to know about this data set. Okay. So likewise, there are other platforms also where you can get the data set, but this is one of the good platform here, Maven Analytics. Just search in Google, and then you go to their website, and here you go to discover. In the discover, you go to resources. In the resources, you go for data playground. And when you click on data playground, you'll be getting these data sets here. Okay, and there are a lot of pages here. There are 13 pages here. Good. Yeah. So now let us come back over here. So see, we have saved this file. Okay, so let us close this file, because we'll be coming back very soon. So let us close this file. Yeah. And now I will request you that you open a blank Tableau desktop file, either Tableau desktop or Tableau public, whichever is fine. So I'll open up again Tableau, Tableau 2024.3. So just open a blank Tableau file. Okay, and now we'll go one by one those concept of data blending, then union and pivot table. And then if time permits, then we will come back to that sample superstore data set, and we'll continue further. Okay. So please open a blank Tableau desktop or Tableau public file. So first of all, I would like to show you here the concept known as data union. Okay, data union. So for data union, we'll be using uh, uh, okay, so see, you already downloaded all these data sets from your LMS. So for the data union, we are having this file, which I've already shared with you, which is known as union demo file superstore.xls. Okay, so this data set, union demo file superstore data set, this will be connecting with the blank Tableau desktop file. Okay, to understand the concept of data union. So let me, yeah, I hope that you all open this file. Okay, blank file. And now I click on this Microsoft Excel. And now I select that file, which is this one, union demo file. Okay, you have already downloaded. So please connect that file, Excel file, union demo file superstore. Click on open. Okay. Now I would like to show you that first of all, that raw data set. So let me show you what is that data set containing. So see, this is that data set. Okay, that original data set here. So I opened that file. You don't have to open this file. It's not compulsory. So in this file, that is union demo file superstore Excel file, you can see that here on my screen that there are these three sheets over here, 2011, 2012, and 2013. Yeah. If I open this 2011, okay, 2011 sheet. So see, it is containing here country, then there is a state, okay, then there is region column, then category, subcategory, product name, sales, and profit. Okay, so 1, 3, 4, 5, 6, 7, 8. There are 8 columns over here in the 2011. Country, state, region, category, subcategory, product name, sales, and profit. Okay, now this is the data of 2011. Now if I go to the 2012 sheet, the 2012 sheet is also containing the same columns. Same columns, okay? Country, state, region, category, subcategory, product name, sales, and profit. Okay, but this is the data of 2012. And then if I go to the 2013, 2013 is also having the same thing. Okay, country, state, region, category, subcategory, product, sales, and profit. So here what we are having the data of 3 years. And now what we want to do, we want to do the analysis. Now see, I cannot do the, if I do the analysis individually, let's say for 2011, 2012, 2013, if I do it separately, it doesn't make any sense here. So what I want to do here, I want to add all this data of 2011 plus 2012 plus 2013, and then I want to do the overall analysis. And then I want to know that, okay, say whether the sales have increased or decreased over the period of time, or whether the profit has increased or decreased over the period of time. Yeah, because I cannot do it individually here. It doesn't, yeah, make any sense here. So that's why I want to combine these 3 data set into one data set. And what is the situation here? That here in these 3 data set, the number of columns are same and the titles are also same. Remember this thing. The title should also be same. If here if it is written here country, yeah, okay, and in the other data set if something else is written, let's say it is written country name, then country and country name are different according to Tableau. And according to Power BI also it is different. Okay, so country and country name titles are different. So what I have to first of all check, if I'm having these kind of scenario, what I have to check that whether all the columns are having the same names in all the 3 fields or in all the 3 tables. If here it is country, then in the other 2 tables also you should have the country column. Yeah, you should not have different name here, different title here. So in this situation, we are having the same number of columns, same column titles, but the data is different. Okay, so that's fine. So now what we'll do, we will combine these three tables into one table, and then I will do the analysis. So here we are having the concept known as data union. And this data union is similar to the append queries technique in Power BI. In Power BI, you must have gone through that concept of append queries. What is append queries? In append queries also, we are doing the same thing. We are putting the one table below the other table. And append queries is also used when you are having these kind of situation that the number of columns are same and the titles are also same. So whatever the topic that we are having in Power BI that is known as append queries, here in case of Tableau, it is known as union, data union. Yeah, concept is same, only the names are different. So what we'll do now, we have connected this union demo superstore file over here, and we can see the three tables here, three sheets. So first of all, what we'll do, we will bring this 2011 table over here. Yeah, bring the 2011 over here. So see, now 2011 is over here. How many fields it is having? 8 fields, 8 columns, and how many number of rows are there? 3270. Okay, so this also I'll write down somewhere. So 3270 rows are there. Yeah, in the 2011. Now what we'll do, I'll drag this 2012. First of all, you focus on my screen what I'm doing, how to do the data union. I'm dragging this 2012 over here. And now what I'm doing here, see, if I bring it over here, then you can see that this noodle is created. A noodle is created. I don't want to create a noodle. I'll bring this 2012 over here near 2011. So see, when you bring this 2012 near 2011, you see this word union. You should be able to see union. If I go a little bit far away, then I'm not able to see the union word. I have to come nearby 2011 and then I have to drop it. I have to drop this 2012 onto this word union. Yeah, so I drop it this 2012 to this union word. And now you see here this icon has changed. If I put my pointer on this 2011, what it says here, logical table 2011 and union tables is 2011 2012. Yeah, just put your pointer over here. Yeah. And if I double click here, if I double click here, you can see that I can see that there is 2011 plus. Here it is written plus. It says here 2011 is made of two tables because there is 2011 plus 2012. Yeah, if I close it, if I click on this cross button here, so see, this is your data union. And now you see here how many fields are there? 10 fields and 5,898 rows. Now see, the number of rows have increased. So 5,898. Okay. See how many actual columns are over here? 3, 4, 5, 6, 7, 8. So normally there should be 8 columns here, 8 fields. But now what has happened here? The number of fields have increased, 10. Yeah. And why it has become 10, then also we'll see further. So now here in this 2011, I am having 2011 plus 2012. Now what I do, I drag this 2013 and I bring it over here nearby this 2011 and then I drop it on the union area. Okay, so I drop this 2013 on this union area. And now if I put my pointer here, you see it is written logical table is 2011 and union tables is 2011 plus 2012 plus 2013. Okay, and now you see here 10 fields and 9,872 rows are available. So see, the number of rows are getting almost double and 3 times now. When we had only one table 2011, the number of rows were 3,270. When we added the 2012 to 2011, the number of rows became 5,800 something. And now when we are taking the 2013 and we are adding it to this union table, the number of rows have increased to 9,892 rows. And this number of fields are 10 fields. Why it has become 10? Because let us focus over here. Yeah, you see here, country is there in our data set. Country, state, region, category, subcategory, product name, sales and profit. So see, this 8 columns. How many columns are these? 8 columns. Country, state, region, category, subcategory, product name, sales and profit. So 8 columns are also available in our original data set. So see, when I add this 2011 plus 2012 plus 2013 in my final table, I should be having only 8 columns. But what you are able to see here, we are able to see here total 10 columns. Why these 10 columns have come up here? Because if you see the last 2 columns here, what are these last 2 columns? These last 2 columns have been created by Tableau. We have not created these last 2 columns. It has been created by Tableau. What is the last 2 columns here? First column, the second last column is known as sheet. So see, these are the sheet here. How many sheets we are having here? 3 sheets, 2011, 2012 and 2013. And we are also having here another column which is known as table name, 2011, 12, 13. So here, these 2 columns have been created by Tableau, not by us. So our actual columns are these 8 columns. But because we have done the union, that's why these 2 columns have been created by Tableau. I hope that you are able to understand this thing. Yeah, clear this point? Okay, you will ask me a question that Samir, we are having in the original tables only 8 columns. Why here we are having 10 columns? Because of these 2 things. Because these 2 columns have been created by Tableau. Okay. Now, here we are having sheet and here we are having table name. So if you see the sheet and table name, they are having the same data. Okay. So what we can do here, we can hide one of these column because I don't want to have these 2 columns which is having the same data, because both are showing you here 2011. This is 2011 and then it will show me 2012 and then it will show me 2013. So I don't want to keep both these columns. It's a data duplication here. So what I can do, I can make one of these column, let's say this table name column, I can make it hidden. I can hide it because I cannot delete it. Okay, I can just hide it. So what I'll do, I will go to this table name column and I can just hide it. I click on hide and see, now this one column is hidden, table name is hidden. Okay. And now here it is written sheet. Now see, sheet doesn't look good here. The title is not looking good. What I can do, what are this one? 2011, 12 and 13, these are years. So instead of sheet, I can double click the sheet and I can write down here years. Years. See, double click here sheet and you write down here years. That's the proper title. Yeah, so I also require this years column, because if I want to do the analysis of sales and profit over a period of time, I require this years column. So instead of sheet, I have changed the name to years. That's all. Okay. So now I'm having how many fields? 9 fields, 9 columns. And the number of records are same, 9,892. So this is how you are doing the data union. Now remember this thing that in this example, we were having one file, one Excel file, and one Excel file was containing different sheet. It is not compulsory that every time you'll have this thing. It is possible that you may have different Excel files. One Excel file will contain the data of 2011. Another Excel file will contain the data of 2012. Third Excel file will contain the data of 2013. So what you can do here, you can bring all those Excel files one by one here. Yeah, because this kind of situation will not be always in your company. Yeah, every month you are getting one Excel file. Yeah, so you have to bring this Excel file over here. Okay, and then once you bring the Excel file, you'll be able to see the different sheets here in the Excel file, and then you can simply drag that sheet and create the union. That's all. Okay, the concept is same, but Here in this example, we are having one Excel file, and one Excel file is containing various sheets. Yeah, but it's not compulsory every time. Yeah. So once we have created this data union, yeah, now I can go to the sheet 1 below. We can click on the sheet 1 here, and now in the sheet 1, what I can do, I can drag, let's say, these years. I drag the years in the columns, and I can drag the sales in the rows area. So see, years, I can put it in the columns, and I can drag the sales in the rows area. And now this is a column chart. Okay, let me make it entire view. Entire view. I'll do the sorting. You know the sorting button. Either you can click these two sorting button or this button. So sorting, and now I can see that in 2013 the sales was maximum, followed by 2011 and then 2012. Yeah, I can also create a line chart here if you want. I can go to show me. In the show me, if I click here show me, I can click on this line chart, this one. Okay, I can click on this line chart, or for lines, okay, lines, okay, no, sorry, lines, it requires one date field here, date field, okay. So I cannot create a line chart here. Why? Because see, this is here we are having only years. There is only year 2011, 12, and 13. We are not having the exact date. If here we would have some date column like order date, ship date, then I could have created the line chart. But here you can see that I cannot click this line chart here because it is telling me that for line chart, I require one date field. Okay, so there is a difference here. Date field is different and this year column is different. It is only containing here year. It's not a date. Yeah, so I can create this kind of column chart and I can do this kind of analysis. Yeah. So this is what we mean by data union. I hope it is clear. Any question from your side? Yeah, anything which you could not understand in this data union? So first of all, you bring all the sheets or you bring all the Excel files to your Tableau, you connect with your Tableau, and then you do the data union in the data source area. Let me click on this data source here. You do the union over here, and then yeah, you can come to the sheet 1, and then you can create such kind of thing. We use union when data is more than one. Yeah, definitely. Yeah, because if you are having one file, it doesn't make any sense. Yeah, so you should have at least two data sets which are having the same number of columns and same titles, and you can do the data union. Data union is clear. So what you can do, if you want to save this file separately, you can click on file, save as, and let me also save this file. Yeah, for each topic I want to create a separate file so that you can see those files properly. Okay, so I'll save here this file as day 2, and I write down here data union. Okay, just for my reference here, day 2 data union, and I save here as .twbx. Remember this point, .twbx. Now see, one of the advantage of .twb is this, that .twb file will be smaller file. Smaller file means it does the size of that file will be small. Why? Because you are not attaching the data set in the .twb, while the .twbx file will be always a larger file, a big size file. Why? Because the data set is also attached over here. Okay, so our data set is containing only 10,000 record, but if you are having a data set which is containing, let's say, 100,000 record, then definitely your .twbx file will be very, very large enough. Okay, so you have to decide. Yeah, I am not saying that .twb file is a very bad file, bad option. The advantage that we get with the .twb file is that the file size will be small, because there is no data set attached with that file. Okay, if you know that your colleague is already having that original data set, then you can just send them the .twb file. But remember that this file that you are sending it to your colleague, it is because that your colleague will also help you in creating the visualization. If you are sharing this file with your users, with your business user, then you should not say or say you should not send this .twbx file. If you want to share this report, this Tableau report with your business users, then either you can use Tableau server if your company is very large enough, or you can use one another concept known as Tableau Online. In the Tableau Online, you can create your account, and then other people can also create their account, and then I can share this file with my other business users through the Tableau Online. Tableau Online is much more cheaper because in Tableau Online, I'm just giving the money per account. Okay, so if my organization is small and if there are, let's say, 20 users only in my organizations who are using Tableau, I can go for Tableau Online. But if there are, let's say, 500 users, 600 users, 1000 users, then it makes sense to go for Tableau server. Okay, so in the Tableau server, you'll have the data set also. You can store the data set. You can also store the report, and you can also provide the access to the reports in the Tableau server. So these are the advantages of Tableau server, but they are very costly. Remember this point, okay? You can check with the Tableau team. I don't know the exact figure. Yeah. So let me save this. First of all, this file, I'll save it with .twbx, day2 data union. Okay. Let me check here. Tableau server pricing. Let us see if something is there here. Tableau pricing. I don't know whether it will be there or not. Normally, they will not share this information. You have to ask them specifically, and then only they'll be able to share. Okay, so here also Tableau server. Yeah, Tableau server also you can try it for free if you want. Yeah, but there is also this Tableau online. Okay, this is the new Tableau online. Okay, so these are the various pricing here. You can check it. This different pricing here. Enterprise viewer. See here, suppose if you are providing the license to your user, business user, okay. Now see, business user will not be creating any visualization. They'll not be creating any Tableau report. So for them, these kind of licenses are very good. That is enterprise viewer license. Okay, this is $35 per user per month basis, and they are billed annually. Okay. And if you want to give the license, a Tableau license to a Tableau developer, then the Tableau developer should have this Enterprise Explorer. Okay, so that is costing $70 per user per month basis. Okay, but just for viewing purpose, you require this license, which is cheaper, almost. Yeah, this is half. Okay, so here you can save your money. You have to decide that, okay, how many people will be developing the report and how many people will be viewing the report. So for viewing you are having this license, and for developing you are having this license. And here it is little bit much more expensive. Discover insight with powerful suite of products that support your end-to-end. Yeah, so here you'll be having some extra features here. I have to go through this thing here, but here it says Tableau desktop. It includes Tableau desktop, Tableau prep, and one creator license. Yeah, so here you are having additional features. That's why they are costing here 115 dollars per user per month basis. Okay, so you can check this thing, Tableau pricing. So I think so Tableau, this union part is clear. We'll open another Tableau desktop file, a new file, and now we'll be going for the concept known as pivot table. What is this pivot table? So now we'll be going for the next concept, which is known as pivot table. Okay. Now all of you know this pivot table because we discussed this thing in the Excel course. Now here we can also do the pivoting of the table, pivoting. So what we'll do now, we will use this data set. Which data set here? Let me show you the data set. We'll be using this data set, which is known as pivot data.xls. Okay, so now we'll be connecting this Excel file, pivot data.xls, with the Tableau file, with a blank Tableau file. Yeah. If you have not downloaded this data set, please download it immediately and we connect it with our this Tableau desktop or Tableau public. Yeah, let me close this file. Okay, so just open a blank Tableau file. I click on Microsoft Excel and now I'll be connecting that this one. Yeah, pivot data or pivot data, whatever you say. Okay, so pivot data or pivot data, this Excel file I'll be connecting with Tableau desktop or Tableau public. So see here, you can see that we are having sheet 1. Now see, if your Excel file is containing only one sheet, then automatically it will come over here. You see here, I did not drop the sheet 1 here, it automatically came. Because in my Excel file, if I open that Excel file, that pivot table or pivot data, let me show you that pivot data Excel file. So see, this is that Excel file which I'll be which I have now connected with Tableau. So this Excel file I have just created a demo. Okay, this is a demo file. So here there are some products. Okay, and there are these. You can assume that these are the sales figures for various financial year. So financial years 17, 18, 19, 20, and 21. And these are the products. Okay, phone, television, PlayStation, home theater, router, smartwatch, laptop. This is just a demo file here. So now here you can see that I'm having separate columns for each of the year. Yeah. Now, if I have connected this file, okay, with this Excel. So I've connected the Excel file with the Tableau desktop. Now, here we are having these separate columns. So whenever you are having these kind of situation where you are having separate columns for each of the year or separate columns for each of the month, then this will, if you directly use this data set, and if I go to sheet 1, suppose, if I go to sheet 1 here, and now if you tell me that, okay, yeah, if you ask me that, okay, Samir, I want to see the sales figures, I want to analyze whether over a period of time, whether the sales has increased or decreased for each of the product. Yeah, so I want to create here, let us say a column chart. Okay, and I want to do the analysis of the sales figure for each of the year. So here, what is happening that if I go to sheet 1, I can see these various columns. Okay, so suppose if I put this product into the columns area, then what I have to do, I have to drop here 2017, 2018, 2019. You see the issue here? I have to put here separately each of these fields, and now I'm getting these kind of visualization. It is not making any sense here. Yeah, I cannot analyze these kind of visualization. I want to create here a column chart for each of the product, and I want to analyze their sales figures for each of the year. Okay, so this is the issue here, that I can, if I keep these years separately, then it will not help me. So what I want to do, I want to remove this. See, first of all, I'll show you one technique here. If you have created some visualization here, and if you want to delete that visualization, how to delete the visualization? You are having one button here. Yeah, this is that button which is on the left hand side of this swap button, this button. If you click this button, then this visualization will go away. Okay, so if I click on this button here, The visualization is gone. Very easy. Okay, so remember this button here. If you want to clear, it says here clear sheet. Okay, so I'll go back to the data source below. You can see here at the bottom area, bottom left corner, data source. I click on data source. So just now what is happening that I cannot keep this years column separately. So what I want to do now here, I want to do the pivoting. What is pivoting here? I want to convert these 5 columns into 5 rows. I repeat, I want to convert the 5 columns into 5 rows. Now in case of Power BI, have you gone through that concept of pivot and unpivot? Yeah, in Power BI, we have one concept known as pivot and unpivot. Have you gone through that concept here? Yes, okay. So pivot means, in case of Power BI, pivot means you are converting the rows into columns. And in case of Power BI, the unpivoting means you are converting the columns into rows. So in Power BI, we are having separate two topics, pivot and unpivot. While in case of Tableau, both pivot and unpivot are overall known as pivot. Here we don't have that concept of unpivot. Yeah. Though we do the unpivoting, in unpivoting, here what I'm doing, I'm converting the columns into rows. So it is unpivoting. But according to Tableau, it is known as pivot. Okay. So here we don't have separate concept. The whole thing is known as pivot. Whether I do the pivoting or whether I do the unpivoting, in Tableau, it is overall known as pivoting. So how to do the pivoting here? You select this first column, 2017. And now you press the shift button, because see, you want to select all these 5 columns. You press the shift, you select the first column, 2017, press the shift button, and now you select the last column here, 2021. Okay. When you select the last column here by pressing the shift button, you see that all the 5 columns are selected. So even if you are having 100 columns, you should not worry. Select the first column, press the shift button, and then you select the last column, and then all these columns are selected. Yeah. Now what we want to do, we want to convert these columns into rows. So here I have to click this, any of this drop down arrow. Yeah, either I can click here or here, anyone. I can click the drop down arrow. And now here we have this option known as pivot. Pivot here. You see here, there's option pivot. Click the drop down, any one of the drop down, click on pivot. When you click on pivot here, you are now having here, see, phone. See, now there are different records here. There are duplicated records, but why they are getting duplicated? Because here you are having 5 years. And these are the pivot fields values. Okay, so see, these 2 columns have been created, pivot fields name and pivot fields value. These 2 titles are given by Tableau. Okay, in case of Power BI also this happened, that when you are doing the unpivoting or pivoting, Power BI is giving its own title. So now what we can do, this pivot fields name, I can double click and I can write down here financial year or FY. Okay, I can write down here FY, financial year. And here I can double click pivot fields values. I can double click and I can write down here, let's say sales, because these are the sales values. So I write down here sales. So see, this is the product column, this is financial year, and this is the sales. Okay. So I have changed the title here. And now my job is done. I can go to the sheet 1. I go to the sheet 1 and now I can drag here. I can drag this financial year in the columns area, and I can drag the sales here, sales in the rows area. And now I can see the column chart. Yeah, I can make it entire view, and now I can click this sorting. You see here, 2020 is having the highest sales, followed by 2019, 2021, 2017, and 2018. I did the sorting here. So what I have done here, I put the financial year FY into the columns area, and I've put up the sales, and now you see here it is very easy. So this is what you can do with the pivoting. That when you are having many columns like this, so it is very difficult to analyze all those columns together. So convert those columns into rows by doing the pivoting, and then you can put it into the visualization. This is the concept known as pivot. Suppose if you are having two columns like male and female, yeah. So instead of keeping those two columns separately, what you can do, you can select those two columns, male and female, do the pivoting, and then you can create a gender column. Okay, so there will be one gender column, and then there will be one numerical column. Numerical column, it can be sales, profit, anything. Yeah, so rather than keeping those two separate columns, male and female, convert it into, do the pivoting, and then you create those two columns. One is gender column, and once you have the gender column, then you can do the analysis that, okay, you want to see that which gender is having how much sales, or which gender is generating how much sales. Yeah, so it is better rather than keeping those two separate columns and then putting over here. It is difficult. So you can do this pivoting in some situations like this. So please save this file always. So file, save as, and I'll save it as .twbx. Okay, and I'll use this one, that is day2 underscore pivot data. I'll give it like this name, day2 pivot data. Click on save button and save it as .twbx. Pivot data, this is the file, you can close it. Okay, and now finally we'll be going for the next topic here. Maybe it will be the final topic, and let us see if we are having some time. We'll switch back to that sample superstore data set. But now I'll be going for the next topic, which is known as data blending. Okay, data blending here. So for data blending, we'll be using these two files, that is office sales.xls, and another file will be coffee sales. Okay, so office sales and coffee sales, these two files will be connecting with our blank Tableau desktop file. Okay, so we are going for the next concept, which is known as data blending. Now let me see some theory part over here. See, we have seen this union part. Union we have already seen. Okay, now we are going for the data blending. Okay, so what is data blending here? Data blending, it says that blending is a method of combining related data from multiple sources in a single view to analyze it. So it is a method of combining related data. Now related data, what do you mean by related data? Let's say I'm having a employee data. I'm having a department data. Okay, so there are two tables here, employee table and the department table. Now they are somewhat related. Okay, so employee data will also containing the department information. Let's say if I'm working in marketing department, then it will show me that, okay, in my employee data, it will show me that, okay, employee ID 101. Yeah, then it will write my name and surname, Samir Wadia. Then it will show that, okay, I'm working in marketing department, and then it will show other details about me. Okay, the salary and the gross salary and the net salary. And then there is also another table which is known as department table. In the department table, only the department number and the department name will be written, and their location will be written. Okay, so if the marketing department is there, that the marketing department ID will be 101 or 01, let's say. The department name will be marketing and the location will be, let's say, Frankfurt. Okay, so this is how this kind of related tables, if you are having, and if you want to bring it together in Tableau, remember that the tables here that we are bringing over here for data blending, the number of columns are not same. The titles of those columns are not same. Okay, in the data union, what we saw that in the data union, all the number of columns were same and the titles were also same. So we went for data union. But in the data blending, that's not the situation. Employee table will contain 10 columns or 15 columns, and department table will contain 3 columns. But what is the main purpose over here in the data blending? That when I'm connecting one table with another table, yeah, then I should be having one common field, minimum one common field. There should be one common column between the two tables. Then only I can do the data blending. Yeah, and both are coming from, both can come from different data sources. One will be coming from SharePoint, another will be coming from let's say SQL Server, or one is coming from Oracle Server, second one is coming from SQL Server. I can connect those two tables with the help of data blending, and both the tables are containing different columns and different column numbers. Okay, in that case we go for the data blending. Okay, so here it says data blending is a method of combining related data from multiple sources in a single view to analyze it. Yeah, so this is some primary data source, secondary data source. There is also one more table from secondary data source, and then here it says Tableau identifies the common dimensions within the data source. Common dimension means the common field, which is the common field between the two tables, and then with the help of this common field, it will connect the two tables, and that two tables will be connected with the third table. The whole table will be connected with the fourth table likewise. Okay, so this is what we mean by data blending, and now I'll show you the practical part. So let me open a blank Tableau desktop file. You can open a blank Tableau desktop file. Now you see here, if you are having the trial period, every time when you open this Tableau desktop, then it will give you this kind of message, this window here. Your product trial ends in 13 days. You can either continue trial or activate the product using your product key or credential. Okay, so I click on continue trial. Okay, so every time it is reminding us that you don't have the actual version, you are using the trial period here. So now what we'll be doing here, we'll be connecting those two data set. I've already mentioned this data set, office sales and coffee sales. One by one we'll be connecting here. Yeah, so first of all we'll be connecting, let's say, coffee sales, suppose, just an example. Okay, so I click on Microsoft Excel and I click here, let's say coffee sales, the first file. Click on coffee sales, I click on open. So here you can see that we are having the coffee sales, that's the file name. Coffee sales is the file name, and within this file we are having one sheet which is known as coffee chain sales. This is the sheet name. Let me show you that file. If I open that file, Excel file, you see here, this is that Excel file. Okay, so this is that coffee sales file, and coffee sales files is containing this sheet known as coffee chain sales sheet. And here what we are having the product type, product, state, type, region, and coffee sales. So these are the various product type like coffee, espresso, yeah, herbal tea and tea. Let me open that another table. Okay, that is the office sales. So this is that office sales file which I opened. On the left hand side you can see the coffee sales. On the right hand side you can see the office sales. So in the office sales also we have here state code, state, market, market size, territory, and office sales. Now see here I've given some color. There is a yellow color here, there is a green color. So what is this yellow color here? That here it is showing me that there are these two columns which are common. Okay, the state column is also available in the coffee sales, and in the office sales also we are having the state column. So as I said earlier, that for the data blending you require at least one common column. Without that column you cannot do any data blending. You require at least one common column. Yeah, so State column is here is common, but also you can see here that we are having the this one, that is the region column. You see here there is a region column. In the region column also we have here north, east, west, south. Okay, and here we have a column which is titled as territory column. But if you see the territory column, it is also having the same data, north, east, west, south. So the titles are different, region, and here it is territory, but the data is same. So here we can see that there are two columns which are common between the two tables, state column and the region column. Okay, so we have to remember this information. Now what I do, I go to this coffee sales. Okay, so I've brought here the coffee chain sales. Yeah, and this is the 6 fields and 13 rows. Okay, so this is there. Now what we do, that now I want to now bring the office sales here. I brought here the coffee sales, and now I have to bring the office sales here file. So what I have to do now, you see here there is one cylinder here on the top left corner. Here there is a cylinder. I have to click that cylinder, this above area. I click the cylinder, and in the cylinder I can see this coffee chain sales, bracket coffee sales, and now it is giving me another option known as new data source. Yeah, so click this cylinder icon, drop down, and now you click this new data source. Once you click on the new data source, yeah, when you click on the new data source, then you are getting this blue dialog box again. What you have to do, you have to click this Microsoft Excel again, because your file is Microsoft Excel. This office sales is also Microsoft Excel. So I click on Microsoft Excel here, and now what I have to do, I have to go to that folder where my data trace is available, and now I have to select this office sales. Okay, I select this office sales here, and once I select the office sales, I click on open, and now you see here this is my office sales. The sheet name is Office City Sales, and see it is having 6 fields and 18 rows. Okay, so this is how we bring the two files one by one. First of all, I brought the coffee sales file, and then I click on this icon, this cylinder icon. Now you can see that I'm able to see the two files here, coffee sales and office sales. But if I want to bring another file, I have to click here this button, new data source, and it will come over here. Clear? Yeah. Now I have brought both the files to Tableau. Now what we have to do, we have to click on the sheet 1 here below. Click on the sheet 1. When you click on the sheet 1, so now here you can see on the top area, this area here, you can see that we are having both the files, or both the data set, you can say, coffee sales and office sales. Now see, if I click on this coffee sales, this first file, first data set, I can see all the dimensions and measures of the coffee sales. If I click here office sales, I can see all the dimensions and measures of the coffee sales. Okay, this is how I can see this thing. Now what I'll do, I will click on coffee sales, and now what I have to do, that I have to create the relationship here. Once I bring both the files to Tableau, then I have to create the relationship. For how I can create the relationship, by connecting the common field between the two tables. Which are the common fields over here? State, and region, territory. Okay, so I have to tell Tableau that these are my common field. Okay, so I have to create the relationship here. So for creating the relationship here, I have to go to the data. Click on this data tab here above. Okay, on the top area after file, you can click on the data tab. In the data tab, you are having one option here known as edit blend relationship. Edit blend relationship. Okay, so click on the data tab and you click here edit blend relationship, and now here you can see this dialog box which is known as blend relationship. In the blend relationship, it says here blend relationship determine how data from secondary data sources are joined with primary data source. Now here in my case, my primary data source is coffee sales because I selected already the coffee sales here on the top area. So my primary data source is coffee sales and my secondary data source is office sales. Now in your case, if you are having primary data source as office sales and if your secondary data source is coffee sales, you don't worry. Yeah, you can go for any one of the primary data source. So primary data source in my case is coffee sales and secondary data source is office sales. Now here you can see that it is written here state. So Tableau has already identified the common field between the two tables, state. Okay. But Tableau has not identified the another common field which is region and territory. Why? Because the titles are different. Okay. If the column titles are different, Tableau will not be able to identify. But now we have to tell Tableau that no, this region and territory is also a common field between the two tables. Just like state, region and territory are also common field. So here we can see state, that's fine. But now I want to create here another relationship between the region and the territory. Now how to create the relationship? I have to go to this. See on the top area, you can see here automatic and custom. When automatic is there, then in automatic mode, Tableau will identify the common field which are having the same name. So see in automatic, it is showing you state. But now if I want to create the relationship between region and territory, I have to click here custom. I have to click here custom, select here custom option. And once you select the custom option, then you have to click here below add button. Okay, click on the add button here. After clicking on custom here, you click on add button. And when you click on add button, then here it says add/edit field mapping. So now you have to tell Tableau that this region and territory, they are matching. Okay, so here it is showing me primary data source. Here it is showing me secondary data source. What I've done here, I've selected here custom. Again, I'm repeating the step. I've selected here custom option, and then I've clicked on the add button. I click on add button, then this comes up over here, this dialog box. Now here I have to select region on the left hand side, or if you are having territory on the left hand side, you select territory here, and here I select territory. So see region and territory, you select like this. So this is how we can tell manually Tableau that this region and territory, they are linked. They are the common field. So region, I select here territory, I click on OK button, and now you can see here that field has also come up here, region, territory, and state. That's all. Okay. It's not compulsory that you have to bring here another common field also. You can also just keep it here state. That's also fine. No issues. Okay. It's not compulsory that you should have two common field. Minimum one common field has to be there. But here in this case, we are having two common fields. Now, once I have identified the two common fields, I have to click on OK button now. Click on OK button. Okay. So now these two tables, coffee sales and office sales, they are connected with each other with the help of that common field, state, and territory region. Now what we do, we create the visualization here. Let's say the state. Okay. Let me drag here the state. I put it here in the columns area. Okay. And then, or let me put the state in the rows area because I want to create a bar chart. So I put the state. See, currently I've selected here coffee sales. On the top area, I've selected here coffee sales and I drag here, I've dragged the state in the row section because I want to create a bar chart. And then what I do, I drag this coffee sales. Okay, this coffee sales, I put it over here in the columns area. Drag the coffee sales in the columns area. And now you can see that the bar chart is created. I can make it entire view. Okay, make it entire view. And now you can do the sorting. Yeah, you can click this descending sorting. So I can see here that Connecticut is having the highest sales, coffee sales, and the lowest is Illinois. Okay. So I've just dragged the coffee sales. I've dragged the state over here. Yeah, and I've created a bar chart, and I've done the sorting by clicking this button. Either you can click this button, these two buttons as we know, or you can go to this x-axis area, and in the x-axis area where you are having the coffee sales, you can click that button for sorting. Now you see here when I'm dragging these fields here from the coffee sales, you see that this cylinder, just check this cylinder here of the coffee sales, it is having a blue tick mark here. Yeah, there is a blue tick mark here. When you drag the state and the sum of this coffee sales here, you see here the blue tick mark. Yeah, just focus on this blue tick mark. Now what we do, I click on here office sales. Okay, I click here on the top area office sales. Once I click on the office sales, yeah. Now once I click on the office sales, you see here two things. Okay, this kind of icon, this chain icon or the link icon here. What is this link icon here? This link is that connecting link. So we have connected state with state. Okay, state of office sales, we have connected with the state of office sales. So that is this link here, this relationship here. This is the relationship link here. Okay. And then another link is between territory and region. So see, this link is having a cross here. So currently I'm not using this link here. What which relationship I'm using here? State. I'm not using this territory. Though I have connected here, but here it is showing me cross. Okay. So what I can do now, I can drag here office sales. Okay, from the office sales, I'll click here office sales and I put it over here after the coffee sales. Okay, so drag the office sales and you put it over here in the columns area after the coffee sales. And now you can see that there are these two bar chart. Just select here office sales and then you click here office sales over here. See, now both these links are now active. See, both these links are active. Now here, if I put my pointer on this link, that is the state link, it says here, stop using state as linking field. If I don't want to use the state as a linking field, I can click on it and then that state linking field will be out. Yeah, it will not be used. Or I can also stop this link here. Yeah, if I click over here, you see here, if I click over here, then something has happened here. If I again click here, yeah, it is different here. So here what I've done, in this visualization, I can see that in these coffee sales, I can see here that there are total 3, 4, 5, 6, 7. There are 7 states in the coffee sales. But in the office sales, it is showing me only these 2 states here. Which are the 2 states here? Ohio and Texas. Okay. But if I go to the data set here, let me show you the data set here. So in the office sales, how many states are written here? Texas, Ohio, and Washington. While in the coffee sales, I'm having here Connecticut, California, Texas, Ohio, Illinois, Louisiana, and Florida. So here in the coffee sales, I'm not having the state name known as Washington. Washington is already only available in my office sales. While these 2 states, Texas and Ohio, they are the common states in both the tables. Here also I see Texas, here also I see Ohio. And here also I'm having Texas and Ohio. So that's why you see here, when I'm creating this visualization, when I'm taking the coffee sales first, and then I'm taking the office sales, I can see here 7 states in the coffee sales, and I can see here 2 states in the office sales. I cannot see here the Washington state because Washington state is not available over here. Okay, so it is skipping here the Washington state. It is just skipping the Washington state from the office sales here. And also, if you see this icon here, this tick mark, Okay. See, coffee sales is the cylinder icon is having a blue tick mark, and office sales is having the cylinder is having the red tick mark. What is this blue tick mark and red tick mark? Blue tick mark means that in current situation, coffee sales is the primary data source and office sales is the secondary data source. Now, how we can decide which is primary and which is secondary? So see, primary data source is that data source where we are starting our visualization. Okay, so what I did here, I went to the coffee sales. Okay, I went to the coffee sales, and then in the coffee sales, I drag here state. I drag the coffee sales here. So that's why my coffee sales data set was my primary data source, because I used the fields first from the coffee sales, and then I came to the office sales, and then I dragged this office sales field over here. So that's why in this case, my office sales is a secondary data source because it is having a red tick mark. So blue tick mark is notifying you the primary data source, and red tick mark is notifying you the secondary data source. Okay. Now remember that this primary data source and secondary data source, these are not permanent. I can now show you how to make this office sales primary data source and how to make the coffee sales secondary data source. I can also do like this. Okay. So what I'll do, I will click this clear sheet. Okay, I click on the clear sheet. Now what I'm doing, you just focus over here. I'm going to the office sales here. I'm clicking the office sales data set. So first of all, I'll use the office sales, and then I'll use the coffee sales. So I go for office sales, and now I drag here state. I drag here office sales, and you see here now you see the icon here. You see that blue tick mark here, which is having the blue tick mark. Now my office sales is having the blue tick mark because this is my primary data source, because I have used the fields first of all from this office sales. That's why my office sales is the primary data source. Then what I do, I go to the coffee sales. I click the coffee sales over here, and now I drag the coffee sales field. I put it over here. Okay, I put the coffee sales over here, and now you see these two tick marks. Sorry. Yeah, now you see these two tick marks here. See, now in my case, office sales is having a blue tick mark and coffee sales is having a red tick mark. Okay. So office sales is my primary data source and coffee sales is my secondary data source. So that is what I wanted to highlight here, that it all depends upon which data source you are using first. The data source you are using first will always be your primary data source, and the data source which you are using at the last or second data source, that will be always your secondary data source. So you can change this order also. Yeah. Now you see here, I have first of all taken here office sales, and then I've taken the coffee sales. Let me make it entire view. And if I do the sorting here, descending sorting. So see, now this is my office sales. In the office sales, I can see Texas, Ohio, and Washington. And in the coffee sales, I can see only these two bars, that is of Texas and Ohio. Okay. See, in the coffee sales, we are having 7 states. We are having the data of 7 states in the coffee sales, but here I can see only these 2 states. Why? Because in this left hand side, I'm having only 3 states. So accordingly, whichever state is common, it will be shown over here on the right hand side. And whichever states are not common, they will not be shown on the right hand side. So see, this Washington is available on the coffee sales, but Washington is not available in my coffee sales, so it is not shown over here. And the other data and the other states which are there in the coffee sales, they are not shown over here because they are not matching over here with the office sales. But the concept over here is data blending is this, that you can go for the data blending because many times you'll be using this concept. See, normally you will not work with one table, you'll be working with many tables. Yeah. So, and those tables have to be connected with each other. So if you want to connect the tables with each other, and in case of Power BI, we have that concept known as merging queries. I hope that it was also covered in your training, that merging queries. In merging queries, I can bring the tables which are of different shape and size, and I can connect those two tables with a common field. And in the merging queries, what I do, I'm connecting the two tables side by side. While in case of append queries in Power BI, I'm putting the tables one above the other. And append queries, I use that concept when the tables are having the same columns and same number of columns and same titles. So here in this case, Tableau, whatever we are having append queries in Power BI, here we are having data union concept. And in Power BI, we are having merging queries. Here we are having the concept known as data blending. Yeah, just understand like that so that it will be easy for you. Okay. So this is what we mean by the data blending. Yeah, and this concept of primary data source, secondary data source, this blue tick mark, red tick mark, it always changes. It depends upon which field you are using first from the table. Okay. So the field which you are using from the first table, it will be then that table will be always your primary data source, and the second table will be automatically becoming your secondary data source here. Can you go over how you got all 7 states? See what I did here, I dragged the state field, I have dragged it from the coffee sales. You go to the coffee sales data and you drag the state from the coffee sales. And then you drag here coffee sales value, and then you go to the office sales data set. In the office sales data set, you drag this one, office sales. So this state field is from the coffee sales, not from the office sales. Okay, and then we are getting here the 7 states here. Okay, so please save this file again for your reference purpose. .twbx. Now one small concept. See here, just focus over here. Yeah, you don't have to do anything. This is my Tableau desktop. Okay. In the Tableau desktop, if I'm in this data source area, you can see here on the top area, we are having this connection, live and extract. Okay. Live and extract. What is this live and extract connection here? Currently, by default, it is live. Okay. What is the live connection here? That let us assume that I am connecting one of my table from the SQL server. Okay. I'm using one SQL server, and there is one table in the SQL server. And what I've done, I've connected that table from the SQL server to Tableau. So that is currently live. Okay, I'm using the internet, I'm using the Wi-Fi or whatever VPN, and my Tableau is now connected with the SQL server table. So this is the live connection. Yeah, and also if you are connecting with your laptop, also if you are connecting a data source which is there in your laptop, and if you are connecting with Tableau, that is also known as live connection. Yeah. Now what is this extract over here? Extract. So see, extract is used when we are traveling. Let us assume that today I've got one data set, and tomorrow I'm traveling. So what I'm doing, that I want to utilize my time in my traveling. Yeah, let's say if I'm going from let's say Germany to India, suppose. Okay, so it is a 8 hours of flight from Frankfurt to Mumbai, or let's say Frankfurt to Delhi. So in that 8 hours, and suppose if it is a day trip, day flight, okay, so I want to utilize that timing. Now see, when I'm in the flight, definitely I'll not be having the internet connection. Definitely, see, some of the flights are giving the internet connection, but that internet, you can just check your WhatsApp messages and Facebook and all those things. But I cannot work with the data set. So tomorrow I already know that I'm traveling and I want to utilize that time. So what I'll do, that just now, I'll open my new Tableau desktop file. I'll connect my SQL Server table with my Tableau desktop. So it is currently live. Then what I do, that once the data set is coming over here, then I can click this extract option. Okay, I'll click the extract option, and then when I click on the extract option here, see here it says extract will contain all data. Okay, so it will create an extract. I can click also here edit button. Okay, but we'll talk in much more detail here. But extract, what it will do, extract will create here one file. Okay, it will have some data set which will be attached with this file, this Tableau file. And then what will happen that tomorrow I'll take my flight, and once the flight is in the sky, at some height, then what I can do, I can open my laptop and then I can start working with the Tableau file. Now see, I am not connected with my SQL server. Yeah, because at that 30,000 feet or 40,000 feet, I cannot access that internet, and I cannot access my company's intranet or internet, and I cannot connect my Tableau file with that SQL Server table. So here, what happens here in the extract file, that it will extract will create one, let's say one kind of a demo data set. Okay, it will extract one some records from that main table, and then it will attach with this Tableau file. And then when I'm in the flight, I can work with this data set. I can create whatever the visualization I want to create. And then once I'm back in my office, okay, so let us assume that I'm back in the office after 1 week of my travel. So in the 1 week, definitely in 1 week, new records will be created in my SQL server. Yeah, because every day new records are getting created in the table. So once I'll come back here to my office, then what I have to do, instead of extract, I'll then click on live. I'll again click on live. So what will happen, that whatever the report which I have created here, whatever the visualizations I have created here, now it will have the live connection. It will have the latest data, and all my this whole my report will get updated with the new data. Whatever the data which I lost during this 1 week of my travel, that data will come back to this my Tableau desktop file. Okay, I don't have to recreate all those visualizations. My visualizations are already ready. I have to just go for the live connection, and then again that data will get connected with this Excel file, the latest data, and all my visualizations will get updated, and I'm ready. Okay, so that is the advantage of extract. Normally, extract is used also when your data set is very large enough. Let's say you are having 1 million record. Let us assume like that, or you are having 1 billion record. When you are working with a very large data set, what you can do, you can take an extract of that 1 billion record. Let's say you are taking only 10,000 records, suppose. Okay, you are taking one small data set. You connect with your Tableau, create all the visualizations, and then again when you go for the live connection, your visualizations will get updated with your all the data, and you are ready to go. Okay, so this is the advantage that you are getting with the this thing, extract here. And also extract is used when you are traveling. Yeah, if you want to utilize your time, yeah, definitely you can. When you are in the flight, you want to see some movies and all those things, but let us assume that you are having some deadline and you want to meet that deadline. Then even if you are traveling, you should not worry. You can create an extract file, and the extension of extract file is dot hyper. Just like we just now saw these two extensions, .twb and .twbx, the extension of extract file is always .hyper. So that extract file will be always named as blah 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 .hyper, hyper. Yeah, so that's the advantage we are here. So normally live connection you are using normally when you are working with a smaller data set. But if you are working with the larger data set, then you can go for the extract, or as I said earlier, that you can use the extract option only when say when you are also traveling. Okay, because you are not have any live connection. And remember that this live and extract feature, you are only having when you are using Tableau desktop. only Tableau desktop. Okay. See, if I show you here in the Tableau public, this is my Tableau public here. See, this is Tableau public. In the Tableau public, I don't have that option of live connection, live and extract. Yeah, so I cannot create an extract file in the Tableau public. This is another difference between the Tableau public and Tableau desktop. Yeah, so remember this feature here. Live and extract connection, if you want to have it, this option, you should always go for the Tableau desktop and not the Tableau public. Good. So now let us start. So we'll be connecting the Excel files. As you know that if you want to connect the Excel file, you have to click on this Microsoft Excel. So I click on it and then I go to the data set. Okay. So I go to the data set here. Yeah. In your case, wherever you have downloaded the data set, I'll go to Simplilearn, Tableau course, data files, and here I'm having this Excel file, sample superstore 2024. Yeah, so you connect that data set. Okay, sample superstore 2024, click on open. And now here we are having the three sheets, three tables or three sheets, that is orders, peoples and returns. Now last time we have already used all these three sheets. Now today, from today onwards, we'll be focusing only on the order sheet because that's the main file, that's the main data set. So we'll be using only this order sheet. So simply what we do, as you know, yeah, that we drag the order sheet over here, we put it, drop it over here. So that now we are having this order sheet. Yeah. Why I'm repeating these steps? Because I know that we have come back from 2 weeks, okay, of vacation. So even when I started my my job last Monday, yeah, after this vacation, so it took me some time because whatever I was doing before the vacation, I had to recollect that okay, this is what I was doing. So it takes some time. Okay, so that's why I'm showing you these steps. Otherwise, I know that you are knowing these steps. So order sheet we have put up over here, and we have talked about many times about this metadata. Okay, and this is the table that we are having. So we'll not go into that detail. Now we'll be going for the sheet one. Okay, after we connect the data set, if you want to start the visualization, you know that we have to click on the sheet one below. So we click on sheet one. Let me open my marker also over here. Okay. So here we are having initially we are having all these dimensions. As you know, dimensions are mostly discrete. Yeah, they are having discrete values. So they are shown in the blue color here. All these the data type icons, they are shown in blue color. And you know that these are the measures. And in between the measure and dimensions, we are having here a small line here. Okay, there is a very thin line over here which tries to distinguish the dimensions and the measures. So the measures are mostly numerical, yeah, and they are continuous. So they are shown in the green color here, yeah, green icons. Now what we'll do, we'll start with initially the basic charts over here, and then we will move to the advanced charts here one by one. So first of all, we'll start with our column chart. Column chart, though we have created in the earlier file, but let us create one more column chart over here, the same column chart. So for column chart, you can take any one of the dimension. Yeah, I'll go for, let's say, our basic category. So category, I drop it over here. As you know that we are having here columns and rows. So I drag the category, I put it over here in the columns. So we are having here the category in the columns, and now we can see these three categories here: furniture, office supplies, and technology. Okay, so category is over here in the column section, and then let us take the sales here. Yeah, you can take anything: discount, profit, quantity, sales, any numerical field you can take it. I'll take here sales. I'll drop it over here in the rows section. So as soon as you drop the sales in the rows section, we are having here sum of sales. Okay, it does the aggregation here automatically. Yeah, and here we are having the column chart, a simple column chart. So for the sorting, we are having here this button. Yeah, we also have the button over here, as you know. So let me click on this button here, this button above the sales. So here it has done the descending sorting, and now I can see that technology is having the highest sales, followed by furniture and followed by office supplies. Okay, so this is our simple column chart. Now let me make it here. Now see below we are having sheet 1. Yeah, here. So instead of sheet 1, what we'll be doing, we'll be writing the the column name here. Okay, means the visual name here. So let us double click here sheet 1, and we write down here column chart. Okay, we write down here column charts. Double click and you write down here column chart. Okay, so column chart is ready. Now as you can see here that when I drag the sales and when I drop it over here, it became sum of sales. Now suppose if you say that, okay Samir, I want to see the average of sales, then what should I do? If you want to see the average of sales, you have to click the drop down over here. Yeah, click the drop down over here in this sum of sales, and then you go to this measure where it is written measure bracket sum, and instead of measure bracket sum we can click here average. Okay, I don't know whether I showed this thing in the last session, but here instead of sum I can go for average. Okay, so I click on average, and now you can see it is showing you average of sales. Okay, or I can go for here measure average. Instead of measure average I can go for here, yeah, minimum, maximum, percentile, anything I can go. I can select here. Now what happens here, suppose if I remove this average sales, okay, let me bring over here outside. So now I'm not having here average of sales. Now again if I drop, yeah, again if I drop these sales over here, what it does, it again does sum of sales. So here by default aggregation here is sum. Okay, by default. Now let's say every time if I want to have by default average sales, not sum of sales, I want to have here average sales, then what should I do? Because see, I ultimately what I have to do, that I have to every time I have to click the drop down, go over here, and then instead of sum I have to click here average. But every time if I want to do that, then it will be very tedious process for me and very boring process for me. So what I want now, let's say that every time when I drag the sales or when I drag the quantity over here, it should show me average of sales, average of quantity, not sum of sales and sum of quantity. So what should I do here? Okay, so here if I go to the sales, yeah, this on the left hand side sales, if I click the drop down here, then in the drop down, yeah, sales, you click the drop down here, and then in the drop down you are having various options, and one of the option here is default properties here, default properties. Okay, so again I'm repeating, I go to the sales over here on the left hand side in the data panel, and in the sales there is a drop down here. I click on the drop down, and then in the drop down I go to this default properties, and in the default properties I can see here comment, color, number format, aggregation, and total using. So in the default properties I go to aggregation, and you can see that in the aggregation we are having here by default it is sum. You can see the dot over here. I don't want to have sum as a default aggregation. I want to have here average. So instead of sum, I will click on average. Okay, I click on average here. Okay, so again, if I go to sales, drop down, default properties, aggregation, in aggregation, I can see that now it is default is average. Okay, now let me remove this sum of sales. If I remove this sum of sales here, and now again, if I drag the sales here, okay, I drag the sales field, and when I drop it over here on the rows section, you see it is automatically taking average of sales. Now I don't have to convert it into average of sales. It's automatically there. So every time I take the sales, or I take, let's say, the same thing, I can also do it for the quantity, profit, and discount. So every time when I drop it in this area, either rows or columns, it will always go for the average of sales, not sum of sales. Okay, clear this point? Yeah, default properties. You can check the other default properties also whenever you get some time. Yeah, so set the default properties. Whenever you want to work with the data, you want to say that, okay, I want to have this aggregation only, whether it is maximum, minimum, average, sales, sum, etc. You set it in, yeah, before you start the creation of the visualization. Yeah, so that every time you don't have to change it. Again, if I want to go over here, if I want to do the aggregation, I want to every time I want to go for sum of sales, I go to the sales, click the drop down, default properties, aggregation. In the aggregation, I go for here sum. Okay, I click here sum. Now here, let me change it back to sum. Okay, I can also change it from here. So now my default aggregation is always sum, not average. Now, this is our column chart. Okay, this is fine. Now what we do, we create another chart which is known as bar chart. So let us go for this new worksheet. Now you know that here below we are having the three buttons here, three options here at the bottom area. So the first option here, the first button here, it is for the new worksheet. Yeah, this is for the new worksheet. The second button is for new dashboard, and the third button it is for new story. Now dashboard and stories, that I'll be taking it on the last in the last session. Okay, so now what we'll be doing every time when we want to create a new visualization, we have to click this new worksheet here below. Okay, so click here this new worksheet, and now we are having sheet 2 below. Let us give the name. We give the name here as bar chart. Okay, double click and give the name bar chart and press enter. So bar chart is now here. So here we'll be creating a bar chart. Yeah. Now what we'll be doing here, that in this bar chart, instead of category, let me take the subcategory here. We are having this subcategory. Okay, so I drag the subcategory over here in the columns area. Yeah, drag the subcategory, not the category. Drag the subcategory. So these are all the subcategories. If you count, then there are 17 subcategories here. 17, 1, 7, 17. And categories are 3 categories. So subcategory I've taken here in the column section. And now I take the, let's say the quantity, suppose. Just an example. Okay, I take the quantity. I put it over here in the row section. Okay, so take the quantity or sales or profit, whatever you want to go for it. I have taken here quantity, so it goes for sum of quantity. And now this is a column chart. This is not a bar chart, because as you know that column chart are always vertical and bar chart are always horizontal. Now let us make it entire view here on the top area. Let us make it entire view. So instead of standard, I'll go for entire view. So see, this is fine. Okay. Now what is the problem over here? Yeah, let us focus on this x-axis. Yeah, whatever the titles which are written in the x-axis, let us focus over here. So you can see here that we are having here accessories. So see, the accessories name is not shown properly. It is showing you ACCESSORI. I'm not able to see the full name here of accessories. Then appliances and everything is fine, but here again this furnishing. Yeah, furnishing, I'm not able to see the whole name. So what is the problem here? That though this chart is correct, column chart is fine, but sometimes when you are having so many subcategories like this, or so many, let's say, yeah, discrete values, then what is the issue? That if the names are very big enough, you are not able to see the names properly. That's the issue. So what we can do now, we can convert this column chart into a bar chart on the left hand side of these two sorting buttons here. Okay, so we are having this button over here, and that is the swapping button. So what this swap button will do, it will swap whatever are there in the rows, it will swap to columns, and whatever there is column, it will swap to rows. So this is the swap button, and with the swap button, we can convert the column chart into a bar chart. So I click on this swap button here, and now this is your bar chart. Yeah. Now, what is the advantage of this bar chart? In bar chart, we can see all these names properly. See, I can see the accessories properly, furnishing properly. Suppose even if the names are still bigger, then what I can do, I can put my pointer over here and then I can drag it like this. Okay, so if I want to have here space on the left hand side, I can put my pointer here and with the help of this arrow, I can adjust the size. Okay, so this is the advantage of the bar chart. Okay, so when you are having many discrete values, you want to see it, then it is better that you go for a bar chart, not the column chart. Okay, and if the names are small, then it is fine. But if the names are very big enough, then definitely bar chart makes sense over here. In the bar chart also, if I want to do the sorting, because see here it is, see how the sorting is done currently by default. The sorting is based on the subcategory name. So it starts with accessories and it ends with tables. So it has done the sorting, but the sorting is based on the subcategory names from A to Z. Yeah. But if I want to do the sorting based on the quantity, then what I have to do in the quantity here, yeah, we are having this small button. I click that button, and when I click the button, now the sorting is done in the descending order. Okay, so binders is having the highest quantity. Okay, then comes paper, furnishing. Okay, so just remember that I've taken here quantity. If you have taken sales, maybe the figures will be different. Okay, the subcategories will be different in the sorting. So binders, papers, furnishings, phones, storage, etc. And the last category, which is having the least quantity, is copiers section in my case. Now let us go to the new sheet here, new worksheet. So now we are having sheet 3 here below. Just you have to click this small button here and it will create a new sheet. So now let us go for a stake column chart. Okay, you know the stake column chart very well. You must have created in Excel in case of Power BI also. So stake column chart. Stake column chart means it is having the stakes. Okay. So first of all, what we'll do here in this sheet, we'll be first of all creating a simple column chart, and then we'll be turning that column chart into a stake column chart. So for column chart, what we'll do, let us take, suppose we are having here segment. Okay, one of the dimension is segment. So I take the segment, I put it over here in the column section. So segment, these are the 3 segments over here: consumer, corporate, and home office. Okay, I've taken here segment. Here there is a segment. Now let me take here, suppose profit. Okay, I require minimum 1 measure. So let me take this profit, I put it over here in the row section. So this is a column chart. Okay, segment in the columns and profit in the row section. Let me make it here entire view. Okay, entire view. Every time it is better to go for entire view. Now I want to create here, this is a simple column chart, but I want to create here the stake column chart. Now before I create the stake column chart, you can see that when I put my pointer here on this one column, it shows me here in this white box, segment is consumer and profit is equal to 136,371. Can you tell me what is this name of this white box here? Tooltip. Yes. Tooltip. Correctly. Okay. Yeah, you must have used it in Power BI. In case of Excel also we have the tooltip. So this is the tooltip. So see, tooltip is very good that when we put our pointer, it is showing me the value. But what I want to do here, I want to put here the label. Okay, I don't want to every time put the pointer here and then I should know the value of this profit. I want to always have here permanent labels. So for labels, what we'll be doing now, we'll be focusing on this area. Yeah, this particular area, it is known as marks card. This is known as marks card. The above thing is known as filters card. This is filters area or filters card, you can also say. And this is your pages section. Pages also will be using it. So pages, filters, and marks card. In the marks card, you can see that first of all, here we are having some kind of drop down. Here it is written automatic. I click the drop down. In the drop down, I can see here automatic, bar, line chart, area chart, square, circle, shape, text, map, pie chart, Gantt bar, etc. There are various options here. So I'll keep it here automatic just now. I'll not change anything. Now here, these are the 5 buttons. Okay. The first one is known as color. Second one is size. Third one is label. Fourth one is detail. And the fifth one is known as tooltip. Yeah. So we'll be using step by step all these 5 buttons or areas, you can say like that. Okay. So what I want to do here in this chart, I want to put here the label, data label. Yeah, that you must have seen in case of Power BI also. So what I'll do, if I want to put here the label, now what I've dropped over here, I've dropped here profit. I've taken here profit. So if you want to put here the label on the top of these columns, then what you have to do, very, very simple. You have to take that field. Let's say I've taken here profit. So I'll take this profit field, and this profit field I'll be putting over here onto the label area. You have to drop it. Take the profit or whatever the sales, whatever you have taken in this chart, take that measure, and then you drop it on the label. When you drop it on the label, you see here, the labels are coming. Yeah, very, very easy, the label. And here you can see that it is showing you a icon of label, that is T. Yeah, this is a small icon, and you can see that, okay, what thing is available in the label, what things you have put up in the label. So it is sum of profit. So whatever the things you are putting over here on any of this panel, automatically it will show you over here for your reference purpose. Yeah. So this is how you create a label. Yeah, you have to simply drop that field onto the label area. Yeah, so we'll also use this label in other visualizations also. So this is our simple column chart. Now we want to convert that column chart into a stake column chart. So what we do, it's very, very easy. Let's say I want to see this, the profit. Yeah, currently it is showing me the consumer profit, consumer segment profit, overall profit. But I want to now see that what is the consumer profit for each of the region. Yeah, there are here 4 regions, central, east, south, and west. I want to know the total profit of the consumer segment for each of the region. Yeah. So what I can do here, I have to simply take the region. Yeah, this is one example. I'll take the region here, and what I'll do, I will put it here on the color. In this marks card, we are having the color panel here. So take the region and put it on the color. When you drop the region on the color, now you see this is your stake column chart. Now it is showing you the individual profit over here. I've taken here profit. So it is showing me here that consumer segment profit in West region is 57,710. Here it is 26,000 something. Here it is 43,000 in the East region. And here in the Central region, it is 8,700. And here you can see those colors. Okay, this is your legend. In case of Power BI, what you are doing, you are putting that field in the legend. Here what we are having here a small button or small area which is known as color area. So simply I drag the dimension, I put it on the color, and my stake column chart is ready. So here you can see that now I have put up the region in the color. See, this is the small icon for color, and this T icon is for the label. So see, drag and drop. Nothing to be done over here. Simply drag and drop, and then the visualization is ready. So this is known as your stake column chart. Okay, so let me double click on this sheet. Why my values are different? Srinivas, just check it if you have taken here profit, because see, I have taken here profit. I don't know whether you have taken profit or whether you have taken quantity or sales or discount. Yeah, if you have taken any other thing, then it will be showing you different values. Just let me know whether you have taken only profit. Okay, you are putting something here. So let us give the sheet name here. So this is the sheet name is stake column chart. Now uh, let us do one thing here, that instead of segment here, okay, I remove this segment and let me take here category. Suppose if I take here category in the columns area, okay, and what I'll do here, instead of profit, I'll remove this profit and I will drag the sales here, sales. Okay, if you want to keep the same chart also fine, you can keep it, but just I'm changing this chart. So what I've done here in the column section, instead of segment, I've taken here category. Instead of sales, I've taken here, sorry, instead of profit, I've taken here sales. And here it is showing me the sum of profit here, which is, I don't want to see the sum of profit. I want to now see the sum of sales here. So I remove this sum of profit. And what I do, I drag the sales over here. I drag the sales. Where I drag it, I put it on the labels. Okay, I put it on the labels here. Okay, just I'm doing something over here. Okay, so here we have taken this category, sales, and the region. Now let me do the sorting here. I do the sorting, descending sorting. So now I can see technology, then furniture, and then office supplies. Okay. Now I would like to show you some concepts over here before I go further with the stake bar chart. See, stake bar chart, to create a stake bar chart is very, very easy. What stake bar chart is doing here, that, okay, so now here you can see that like here we have created a plus stake column chart. Now I was telling you that if you want to convert it into a stake bar chart, then what we have to do, we have to simply click that same button here, the swap button here on the top area. If I click the swap button, it becomes a stake bar chart. Yeah, so it's very easy. Again, if I click this swap button, it again becomes a stake column chart. Okay. Now the important part comes over here, that suppose here in this technology, I'm having here, this is the western region sales, then this is the southern region, this is eastern region, and this is the central region. Now as you can see here in the technology category, the southern region sales is very less. Okay, we are having here 148,772. This is the lowest figure in the whole of technology category. Now what I want to do, that I don't want to see this part. I don't want to see this red block over here in the technology column. So what I can do over here. So here I can select this block. Okay, I select this block, and when I select this block only, this southern block in the technology category, then if I put my pointer here, just I put my pointer here on the that red block, I can see here keep only, exclude, then there is this upin icon, and there is this data guide, and there is this create set, and then we are having the last option, that is view data. Okay, again I'm repeating what I've done here. I've selected this red block, And when I put my pointer here, after 1 or 2 seconds, this thing will come up and here it is showing me these various options. Now what I want to do here, I don't want to see this southern block, the red block. So I can click on this exclude option, exclude. Okay, I click on exclude. So see, when I click on exclude, now you can see here from the technology category, see now the technology category position has changed. Initially it was number 1. Now technology category has gone to the 3rd position. Why it has gone to the 3rd position? Because now we are having here no southern region sales. We have removed that southern region sales. We have excluded. So when I exclude the southern region sales, so here you don't see that red block. Okay, and because of that that red block which has been removed, now overall technology is coming at the 3rd position. Now suppose if you want to get that red block back, yeah, so what we can do, we can click on this undo button here. Yeah, on the top area here we are having these 2 buttons, yeah, this undo and redo. So I click on this undo button. If I click on this undo button, my red block is back here, and once my red block is back, my technology is also at the 1st position. Okay, so this is what we mean by the exclude. That if you want to exclude some portions, yeah, I'm just not talking about this red block or anything. You can also exclude a column. Okay, if you are creating a column chart, or if you are creating a bar chart, if you want to exclude it, you can also exclude that whole bar. Okay, this is one of the method of creating a filter. Okay, though tomorrow and day after, in the next weekend also, we'll be talking more about the filters, but this is one of the method of filtering the data, that is exclude. Okay, now let's say I want to compare the Western region sales data of 2 categories, that is technology and the furniture. Okay, or I want to compare the Eastern region sales of technology category and the furniture category. So these 2 blocks only I want to see here. These 2 orange blocks I want to see here in the whole visualizations. I don't want to see these other blocks here. So what I can do, I click this one block, this one orange block. I click it. Once I click it, now I also want to see this block. Okay, from the furniture category. So what I do here, I press the control button. Press the control button on your keyboard. Keep it pressed, control button. And now I can select this block also. So see, 2 blocks are now selected. By default, you can click only one block. But if you want to select here 2 blocks or 3 blocks, you have to press the control button on your keyboard. Keep it pressed. So I have selected here these 2 blocks. Okay. Now, if I want to also select this block of the office supplies, again I can press the control button. I select this block also. So see, 3 orange blocks are selected. I want to now see only these 3 orange blocks. I don't want to see the other blocks here. So what I do, if I put my pointer on one of these block, yeah, now I can see this area here, and in this panel I can see the keep only. Okay, I click on this keep only, click on keep only, and now here you can see these 3 orange blocks only, nothing else. And here now I can compare these orange blocks with each other. Yeah, definitely the technology category is having the highest sales in the Eastern region. What is this orange block? It is of the Eastern region. So here I can see the comparison. Okay, I can do the comparison. Now once my comparison is done, if I want to go back to the original chart, okay, see here, just for your information, you can see that when I'm doing the keep only or when I'm doing the exclude, yeah, either I do keep only or I do go for exclude, automatically here in the filter panel something is created. You see here. Yeah. Now let us go for undo. I click on undo button, so my blocks are back. And if I click outside over here, just click outside, yeah, over here, and all the blocks are back. Yeah, click outside here in the blank area. So this is what we mean by keep only and exclude. Exclude will exclude the block, and keep only will only keep those blocks. Okay. Now here we are having the colors. Now see, these colors are given by Tableau. Yeah, these are the default colors. But suppose if you don't like these colors, let's say you don't like this red color here. Yeah. So what you can do, you can change the color. If you want to change the color here, yeah, we can go over here in this area. Okay, this is the legend. Now in the legend, if I don't like the red color for the south region, what I can do, I can double click here in the red color, this small block. Okay, whatever it is, this block is there. There I will double click. So I double click this red block, and now here I can see this panel which is known as edit colors bracket region. Yeah, simply double click one of these color on the legend. Yeah. Now here I'm having these standard colors. Now suppose if I don't like this red color, instead of red color I want to give another color. So I select here this south. I select south over here, south, and now here I'm having other colors. Yeah. Now see, these are the how many colors are there? There are 10 colors. So I have to select from these 10 colors. But let's say you want to have more colors. Yeah. Then here we are having the color palette. There is a color palette over here. If I click the drop down, in the drop down, I can see here various color palette. By default, it is automatic, but then we are having color palette here. Yeah, click the drop down here, and we are wearing the color palette like Tableau 10, Tableau 20. If I click here Tableau 20, Tableau 20 is having more colors. Then I can go for here color blind. Yeah, color blind colors. Then traffic light. Yeah. Likewise, we are having, you can check all these different colors. Yeah, we can also have single color. Let's say one color, but it is having various shades. So if I go for here blue color, so see I can use here the different shades of blue color. Yeah. Likewise, orange, green, red, etc. Then I can go for two colors here, orange and gold, green and gold, red and gold. Yeah. Now see, in many of the companies I've seen that they have defined their own colors. They are having their own color palette. So in case of Power BI also, we can assign a color palette, our company color palette. And here in case of Tableau also, you can do the same thing. Yeah, there is a method of putting that color palette into one of the folder. Yeah. So if time permits, I'll show you that process. But otherwise, you can, yeah, if your company has created a color palette, then that color palette has to be placed in one of the folder in the Tableau. And then you will be able to see here your color palette also. So I remember that I think so 4 years back when I was doing one project, I was like doing a consultancy project for one of the company here, local company, which was known as Henkel. Though Henkel is a big name, it's a MNC. So for Henkel, they had a Tableau project, and they had told me that Samir, you have to use only our colors. Yeah, so whatever the Henkel is having a red color icon, as a red color logo, so they were having different shades of red color and then gray color, and likewise, so I had to use only their colors. So that makes sense, okay, because otherwise what will happen that everybody will be using their own colors, and if you see all the reports, they'll be not looking same. Yeah, especially the format, I would say. So many of the companies, they have decided their own colors here. So here you can check your colors. But let's say if I go for here Tableau 20, and now instead of red color, if I want to go for here, let's say this pink color. Okay. If I go for here pink color, so now south is shown in pink color. You see here. Likewise, I can select here east color, and in the east I can select, instead of orange, I can select any other color. So this is how you change the color. And once you are done, you can click on this apply button here in this panel. Click on apply. Okay. And now here you can see the pink color. Okay, whatever color you want to select, simply what you have to do, you have to double click over here on one of the color. When you double click, then this panel will come up, and then from the panel you can change the color. And once you are done, click on apply. Okay, and the colors are applied. Good. So this is how you can change the colors. Then here, if you click on this color box, this one color, if you click on this color box here, there also you are having this button known as edit colors. Edit colors. If I click on edit colors, then the same panel will come up here. Yeah, so this is another method. Click on this box color, click on edit color, it will open up this one. And in this below the edit colors, here we are having opacity. Yeah, currently here opacity is 100%, but if I reduce this opacity, you see here the colors are now light colors. Yeah, sometimes initially the colors are very bright, but you don't like the bright colors, then here in the color panel you can change you can reduce the opacity. See, now it is very light. If you make it 100%, it is very dark. So you decide here. Okay, then we are having here effect, which is known as border. You can create here some border here along the colors. Yeah, so suppose if I select here some kind of black border, yeah, some kind of black border here, so you can see that there is some thin black border here. If you want to create, okay, it's not compulsory that you can create here, you have to create here a border, but if you want to create a border, you can select here any color. Yeah, that looks little bit different. Okay, if you don't want to have it, you can click on none here. Yeah, and if you are not liking these colors, you want to have more colors, you can click on more colors here. In the more colors, you can select many colors here. Yeah, so you can do the changes over here also from the color. Okay, so this is stack column chart, and similarly I've told you how to create the stack bar chart, so I'll not now show you how to create the stack bar chart. Just simply you can click on this button and now it is converted to the stack bar chart. Okay, can you change the thickness of the border? Thickness of the border, let me see. No, but color, we are having here opacity, effect, border, but border we don't have any other option here. Maybe here row bending, default colors, total. No, I think so. The border as such, I would see, because see here there is some halo effect, but here it is not showing me any halo effect here. But just now we don't have this option. Maybe if anybody is finding this option, you let me know. Otherwise, I don't see any of these options here. Yeah. Yeah. So this is about the stack column chart. So now let us go to the next chart here, that is known as line chart. Okay, we shift to the line chart here. So line chart is one of the very standard chart. So we'll see that how we can create the line chart here. Yeah, I'm also seeing that whether we are able to, whether I'm missing anything or not. Okay, let us create here. Okay, now before the line chart, let us create one pie chart here. Okay, so let us give the sheet name here, pie chart. Okay, pie chart here. So for pie chart, what we'll be doing, we'll be using this show me here. So now let us use this show me here because we want to create here a pie chart. Yeah. So what we'll be doing here, let's see, for the pie chart, if I put my pointer on the pie chart, you will see something over here that what is required. Okay, so if I put my pointer on the pie chart, then for pie chart, it says that you require one or more dimension and one or two measures. Yeah, you can see over here in this area. So put your pointer on the pie chart and then you will be able to see that information, that what is required to create a pie chart. So what we'll be doing, we'll be taking here, let's say, this is just one example, that I take here region and I want to see the region wise sales in a pie chart. So how to create a pie chart? I select this region. Okay. See, I'm not dragging anything over here. I'm selecting the region field on the left hand side. Then what I do, I want to select here sales. So if I select here sales, then my region is not selected. So I, by default, I can select only one field here. Either I can select region or I can select sales. But if I want to select both the fields, then you know the technique. Control button. Okay. So if I select here region, and now if I want to select here sales, then what I have to do, I have to press the control button. I select the control button, and now I select the sales over here. So you see, both the fields are now selected, region and sales. You can also take region and profit. Yeah, no issues. So I take here region and I press the control button, and then I select here sales. Now what I have to do, after selecting this one measure and one dimension and one measure, what we have to do, now we have to come to the show me, and now you can see that in the show me, some of the charts are activated. The charts which are activated, it means that now you can create those charts. Yeah, so I can create a pie chart, highlight table, heat map, text table. I can create this horizontal bar. This is a tree map. Tree map will also create here. Yeah. So what I'll do, I'll click on this pie chart. After selecting region and sales, I click on this pie chart in the show me. As soon as I click on pie chart is created. Okay, just click on the pie chart here in the show me, pie chart is created. Now what we do here, first of all, I don't want to see the show me panel because I've created a chart. I don't require the show me panel. So I click again on this show me. Yeah, where it is show me is written, I click on it, and now the show me panel is gone because I don't require, and now my pie chart is ready. But what is the issue here? This pie chart is very small. What I have to do here on the top area where it is written here standard, instead of standard, I go for entire view. This is the first process. Okay. So instead of standard, you click on entire view. So see, now your pie chart has become very big. Okay, this is fine. Now you see that still if you are not happy with the size of this pie chart, you want to make it bigger. Yeah. If you want to make it bigger than this size, then for that purpose, we are having here a button. You can see here the button that is known as size button. Yeah, we have already used the color. You know the color button. You know that label button. Now we are using this size button. If I click on this size, then in the size, if I click on the size button, then I can see this bar. Okay. Now let me drag that bar over here on the right hand side. You see here? Now it has become very, very big. Yeah. So when you click on the size button, you can see here that there are these two small, these markings. So here, if I click on the size button, you can see these two small markings. What are those two small markings? These two small markings are showing you the suggestion that if you put this vertical bar, this blue bar, vertical bar, if you put it over here, let me put it over here. So this is a proper good size. But still, if you want to make it bigger, then you can put this vertical bar in the second marking. Yeah, the second marking is another suggestion. So I put this vertical bar on the second marking, and now it has become bigger. But still, if you see here that the size is circle. Okay, the shape is circle here. Okay, it is a proper circle here. But now, if you say that, okay, no, Samir, I'm not happy with this size. I want to make it much more bigger. Then if I drag this vertical bar on the right hand side like this, you see, when I drag the vertical bar on the right hand side, now I cannot see that full circle. It is a pie chart, but it's not a circle now. Its shape has changed. Again, if I go on the right hand side, you see now it has become rectangle. Instead of circle, it has become rectangle. So that's why these two markings are very, very important here. Sometimes you may have two markings, sometimes you may have one marking. And that marking is showing you the suggestion that you can put this vertical bar on that marking. It will be looking very good. So I again put this vertical bar on this second marking. So now it has become proper. It is big enough. And it is also in circle shape. Okay. So this is a pie chart. Now definitely pie chart I can see here, this is the western region, this is the central region, this is eastern region, this is south region. Now I want to put here label. Okay, I want to see here labels. So what I'll do here, in the label option, this label panel, I'll be dragging the two things here. See, first of all, I don't want to see here the legend, because see, if I every time if I see the legend, it is taking me some time. Yeah, so I don't want to see here what is this region, what is this region. So I will put here in the label. In the label, I'll put here two things: region and the sales. Okay, I want to see here in the label region and the sales, so that I don't have to see this legend here. So for that, what I do, I drag the region here, this region, I put it over here. Sorry, this region, I put it here on the label. Okay, so once I put the region on the label, I can see here these four regions. Yeah. Then what I do, I put the sales, because I've taken here the sales. So I put the sales, I put it on the label again. So drag the sales, I put it on the label, and now I can see the label, the sales here too, sum of sales here. So in the label, I have taken here two fields, region and the sum of sales. Yeah, and that is shown over here. See, region is used two times. One region is used in the color, so you can see these different colors, and one region is used in the T. T means label. Then the sum of sales, you can see here sum of sales is shown here three times. Why it is shown here three times? Because one sum of sales we have used in the slice. This is another button known as angle. So for when you are creating a pie chart, when you have to create an angle, so for creating that angle, you require the any numerical field. Either it has to be sales or quantity or discount, anything. So that's why here automatically when you create a pie chart, by clicking this show me here, and if you click on the pie chart, then that whatever the numerical field you have taken, that also goes into creating the angle. So that's why this sum of sales is creating the angle. Then this another sum of sales, we have this is the icon for size, because we increase the size of the pie chart. So that's why this sum of sales is also shown in the size, and this sum of sales, it is shown in the label, because we have created this label 739,814. So this is the label that we have put it over here. So that's why it is showing me here three times sum of sales and two times region. Now here, in case of Tableau, we can create a donut chart. But let me tell you one thing, that donut chart we don't have here in the show me. See, if you go to the show me, we don't have here donut chart. In case of Tableau, you have donut chart. Yeah. But in case of in case of Power BI, you have donut chart. But in case of Tableau, if you want to create a donut chart, then there is a method over here. It's not easy. Yeah. So maybe I'll definitely show you. I'll show you how to create a donut chart. But there are some steps available. It's not like this pie chart that you select two fields and you click on the pie chart and pie chart is ready. No. In the case of donut chart, I don't know why they have made it very complex. But yeah, this is the thing. So in donut chart in Tableau, we have to follow some steps here. Yeah? And we'll continue with this one. And meanwhile, you can save this file, please. Yeah, before we go further, let us click on File, Save As. And I'll be saving this file in that folder, Simplilearn Tableau Batch December 2024. And let me save this file as day 3. And then, yeah, we can write down here types of charts. Yeah, just give some name here, types of charts. And as I said that, let us give here see, save as type. If you remember that I discussed this point, that here when we are saving this Tableau file, we are having two options here, .twb and .twbx. Normally we have to go for .twbx. In the .twbx, whatever the data set that we have used over here, that is the sample superstore data set, that also get connected with your Tableau file. So if you want to send this file to your colleague will not have to connect that data set with the Tableau file. It's already there. But if you save it as .twb here, then you have to also separately connect the file, separately connect the data set. Not you, means your colleague, because when you open your .twb file in your laptop, it's already there. The data set is already there. Yeah, in the laptop, not with the file. But better you save it as .twbx. You save it as .twbx, and here I've given the file name, day 3, types of charts. Click on save button, and now it is done. Okay, so better we save the file. So now let us meet at 9:30 p.m. IST, and we'll continue further. Okay. Yeah, we had discussed this pie chart over here, and we had seen how to create a pie chart, how to give the labels over here. Now, normally in pie chart, I would like to ask you one question, that normally in pie chart, do we see these kind of numbers or we see something else? Percentage. Okay, so normally we try to see it in percentage. So now the question will come here, that can I see here in percentage? Yeah, whether this is, let's say, 30%, 40%, whatever. So I want to see this in percentage. So how should I, or so what should I do here to convert these numbers into percentage? Yeah. So for that purpose, what we'll do here, that we can focus on this thing over here in the marks part, in the marks card over here. So there is a T icon, the label icon, where we are having the sum of sales, and the sum of sales here, I can click the drop down. Okay, in the T sum of sales, I click the drop down, and in the drop down, I go to this bottom area, and here we are having the concept known as quick table calculation. Okay, that instead of these numbers, I want to see it in percentage. So I have gone to this sum of sales, click the drop down, and in the drop down, I go to this quick table calculation. And in the quick table calculation, I can see here running total, difference, percent of total, rank, percentile, moving average. So here, what I can do, I can go for here percent of total. Okay. So here in the quick table calculation, I select here percent of total. And as soon as you click on percent of total here, you say here, now this is the percentage, 31.8, 21.63, 29.74, 16.84. Again, I'm repeating the step. I have to go to this sum of sales, T, click the drop down, and here I go to this quick table calculation. And in the quick table calculation, I can select here percent of total. Yeah. And these numbers get converted into percent of total. Now here, suppose if I don't want to see this decimal number, I want to see here whole figure. I want to see here 31.8 means I want to see here 32%. I want to see here 21.63, that is 22%. I don't want to see this decimal number. So now what I'll do here, I can right click. Now remember my step. What I'm doing here, I'm right clicking on this number, one of the number, or one of this percentage here. So simply I right click on this percentage. When I right click on the percentage, one of the percentage here, then I get here many options. But one of the options that I'm getting here is format. Okay. So right click on one of these percentage number, and then you click here on the option format. Okay. I click on format. When I click on format, then now you can see that on your left hand side here, yeah, on the left hand side, you are having the format panel. Okay. Now in the format panel, we are having here one drop down, which is known as fields panel. Fields. If I click on the fields, this drop down, I can see here region, percentage of total sum of sales, and sum of sales. Now what I want to do here, I want to remove this decimal number from this percentage. Yeah. So here, first of all, what is important here? I have to select here fields, and in the fields, I have to select this option. The second option, that is percent of total sum. Yeah. So I click on this percent of total sum, and once I click on this percent of total sum, now I can do the adjustment over here only for the percent of total sum. Yeah. So this is important here. Now here, what I have to do, I have to go to this pane. Yeah, here there is axis and pane. In the pane, I'm having here default. In the default, I can click here the font. So see, suppose if I don't like this font, I can change here the font. Yeah, I click on this drop down here, and in the drop down, I can see here the various fonts. Okay. Now, the best part of Tableau is over here. One of the best part, that here I'm having many options in the font. Okay. This many options I don't find in Power BI. So here Power BI is having a drawback. You know, this is my view. I can share my view here, because if you know that in case of Power BI, if you want to change the font, you are having, I think so, 10 to 15 or maximum 20, not more than that. Okay. But in case of Tableau, you are having many options here. I have not counted this total number of fonts type, but they are, I think so, at least they are around maybe 100 or so, or 100 and 150. So this is the advantage. So I can select here any of the font which I like it. Let's say I go for this Berlin Sans FB, something like that. I can make it bigger. Okay. Let's say I make it 11, just an example. I can also give some color to this font. Let's say I give here orange color. Okay. And I can make it bold and italics and all those things. I can do it here. So this is where I've changed the font. Okay. I've changed the font. But now, just now you can see that the font is not getting changed. Okay, though I've adjusted here everything, I've changed the font type, I've made it bigger, I have given the color, I've made it bold also, but currently I cannot see the change here. Yeah, but I'll show you where you will see that change, not in the chart. Then I go to the alignment. In the alignment, if I click the drop down here, I can go for here. Yeah, left hand side, middle, and this right hand side, but just now it doesn't make any sense here. I can also make it up, down, yeah, like this, bottom, middle, top. I can also make it like this one. Okay, but I think so. Let me check it here. If I go for fields, okay, alignment will do it a little bit later here. Let us come to the numbers here. Numbers, and the numbers, we are having here various options like automatic, number standard, number custom, currency standard, currency custom, scientific, percentage, and custom. Yeah. So here what we are having here percentage. So I want to remove this decimal figures. So in the numbers, I click the drop down and I select here percentage. Okay, because this is percentage. So I select here percentage in the numbers, and then in the percentage, it is showing me here by default 2 decimal places. Yeah. Now if I want to make it 0, I make it here 0. You see, as soon as I make it 0, you see here, it is now showing you the whole number, 32%, 22%, 17%, 30%. So this is where you can change this numbers here for the percentage. Click the drop down, select here percentage, and you make it 0, and accordingly it will adjust. But before that, you have to select here the field. Okay. If you want to do the modification for this region name, then you have to select here region. Okay, I select here region, and now I can do the font, alignment, etc. Yeah. So this is how we convert that numbers into percentage. Yeah, and that is known as quick table calculation. Yeah, what is quick table calculation means? Tableau is giving you some options. If you click on running total, it will do the running total. If you click on percent of total, it will do the percent of total. Yeah, but in case of Tableau, just like this Power BI, we are also having here concept known as calculated field. Okay, in case of Power BI, it is known as calculated column. Here we are having the concept known as calculated field. So, uh, so I'll be showing you in one of the session how to do that calculations with the help of the formula. But without formula, if you want to do any uh, quick calculation, then you are having the concept known as quick table calculation. Okay, so this is one of the demo over here. Okay, now see, once you are done with this panel here, format panel, let's say you are done with this format panel. So ensure that you are not keeping this format panel open, because what happens that behind the format panel, you are having the data panel. So if I want to see really the data panel, I have to close this format panel. Otherwise, I'll not be able to see it. So you have to close it from here on the top right corner, this X button. If I close it, now you can see that I'm able to see the format panel here. Okay. So the data panel. Okay. So by default, the format panel will be placed above the data panel. And once your job is done, you remove that format panel, close that format panel, and you will be able to see the data panel here. Okay. So this is your pie chart. So we have created a pie chart. Now let us go to the next sheet here. And in the next sheet, we are creating a line chart here. And also sometimes what happens that here, see what I've done here, I've created a dashboard here, though it is not currently required in your case. But normally what happens that sometimes some changes are not shown in the sheet level, they are shown in the dashboard level. Yeah. So normally here it should show you that thing, but here it is not doing any changes. Maybe I have to let me save the file and let me open it again. Yeah, let me try it again here, because some of the changes are taking place in the dashboard, not in the sheet level. Okay, so maybe I will check it again. Normally it should work, but I don't know why it is not working just now here. Yeah, I will check it again. But this the method is same, that we have to right click over here, go to format, and then we have to change the things over here. Okay, I have to select first of all the field, and then I have to select the things. Okay, so that is the normal thing over here. Yeah. Okay, so now we go to the next sheet here, and in the next sheet we'll be creating here a line chart. So normally for the line chart, as you know, that we have to take one date field here. Okay, I have to take one date field, and I have to take here one of the measure. Yeah, so I can take here discount or profit or quantity of sales here. So we are having here two date field, that is order date and the ship date. Yeah, so let us drag here the order date. I drag the order date and I put it over here in the column section. Yeah, drag the order date and you put it here in the column section, and then we drag the sales and we put it here in the rows section, and our line chart is ready. Drag the order date to the column section and sales to the rows section, and this is your line chart. Yeah, let us make it entire view. So now I can see here the sales of 2021, 22, 23, and 24. Yeah, so in 21 the sales was approximately 500,000. Then it became a little bit less in 2022, and then 2023 is increased, and 2024 also it increased. So this is a simple line chart. Yeah. Now you see here, when I'm dragging the order date and I'm putting it over here, see what it is written here, year bracket order date. Now you know that in case of Power BI, that whenever you are taking a date field in the visualization, especially let's say this line chart, then Power BI automatically creates the hierarchy. So you are having year, quarter, month, and then day. Here also the same concept is there in case of Tableau. In case of Tableau also, when you are taking the date field, Tableau automatically creates the hierarchy for you in case of Power BI and Tableau both. Yeah, so here it is showing you year bracket order date, because this is the year level. We are able to see at the year level. Now before the year, we are able to see this plus sign. Okay, here there is a plus sign here. So if I click on this plus sign, so now what happens here? We are having another that pill. It is known as pill, just like medical pill. So we are having a new pill which is known as quarter. Okay, just click over here, plus sign. It brings here second level of hierarchy, that is quarter. So now you can see that we are having here for 2021. This is the line chart. Yeah, where we are able to see the quarter 1, quarter 2, quarter 3, quarter 4. Likewise, there is another separate line chart for 2022, 2023, and 2024. Yeah, so we are having 4 line charts now because there are 4 years. Okay, it is not a continuous line from 2021 to 2024. There are 4 separate line chart. So this is a quarter level. Now, see, when we are clicking on the plus sign in front of year, a new hierarchy level is coming up here, and now in the year, in front of year, you are having minus sign. Yeah. So when you see a minus sign, it means that you can collapse this year, this particular level, collapse. Okay. If I click on this minus sign here, it will again come back to year. Now you can see we are having only the year. Again, if I click this plus sign here, it will show me the next level of hierarchy, that is quarter. Now in front of quarter also we are having plus sign. So if I click here this plus sign, it will show me the month. Now there is another level known as month. So now we are having here, see, this is first quarter of 2021 where we are having January, February, March. So this is one line chart. Then for quarter 2 we are having another line chart, quarter 3 third line chart, quarter 4 fourth line chart, and so on for the other quarters also. So see, there are 4 years, and every year is having 4 quarters. So 4 fours are 16. So 16 line charts are available here. Not one line chart, 16 line charts are there. Okay, they are separated. There is no connection over here. So we are at the month level. Now in front of month also we are having plus sign here. If I click the plus sign in front of month, now we are at the lowest level of hierarchy, that is known as day level. So remember that all these days, which all this in, let's say in January, whatever this line chart is there, you see, as such we have a feeling that this is a continuous line chart. But remember that this is not a continuous line chart. They are all broken line chart. So for every month, we are having here separate line chart. Okay, there is a separate line chart here for every month, and they are not connected with each other. So this is what is your line chart. Okay, and you see the colors here. You see the colors of this pill on the top area, in the columns area, they are all blue color. What is blue color means? It is discrete. So by default, a date field is always a discrete field by default. Okay, and they are all shown in discrete fields are all shown in blue color. Now let's say I'm at the lowest level of hierarchy, that is day level. It is showing me all the days and the sales. Now if I want to come back to the year level, what I have to do? I have to click here this plus sign again in the front of year, and now I'm at the year level. Okay. Now what is the issue here? When I go to the next level of hierarchy, I'm not able to see here a continuous line chart. I'm able to see here different line chart. But suppose if you have a requirement that you want to see one line chart only, whether you are at the quarter level or whether you are at the month level or whether you are at the day level, you want to see one line chart only. If you are having that requirement, then what you have to do, that this date field, currently the date field is a discrete field. Now the discrete field, I want to convert it into continuous field. Okay, if you remember that in the first session I told you that by default dimensions are discrete and by default measures are continuous. But a dimension can be converted into a dimension can be converted into continuous field, and a measure can be converted into a discrete field. Yeah. So now I'll show you here how to convert a discrete field into a continuous field. Currently our order date is a discrete field by default. Now I'll be converting it into a continuous field, and then now we'll see that what is the advantage of converting that order date from discrete field to continuous field. That we'll see the advantage over here. Okay. So let me click here minus sign. I want to be at the year level. Okay. Currently you see the color of this bill. It is blue color. Now, if we want to convert this order date from discrete to continuous, what we have to do? We have to click here this drop down in the year order date. I click the drop down here, and in the drop down, when I click on the drop down, you can see that here this is one portion where it is written year, quarter, month, day, and more. And then below we again have here year, quarter, month, week number, day, and more. Yeah, so there are 2 times here year, quarter, quarter, month, day, and here we are having extra level known as week number, and then we are having day, and then we are having more. So currently you can see that this year is selected. It is having a black dot over here. So this year is selected. Now this is a discrete year. Remember this portion. If this year is selected, it is a discrete year. Now I want to convert a discrete year into a continuous year. So what I have to do? I have to select now this one, this year, the second year. Okay. So if I click this year, so what happens here? You see the color of this order date. It is now green color. What is green color? Green color means continuous field. Again, I'm repeating what I've done here. I've clicked on the drop down here. In the drop down, I've selected this year, not this, not the first one, the second one. Okay, so I click on the second time year, and now it is converted to green area, green color. So now it is continuous. Now you will see what advantage you are getting here. So see, we are at the year level. So in year level, we are getting a one line only, continuous line. Now let me click this plus sign in front of the year. If I click this plus sign in front of the year, you see, now there is a difference. See, when I click on the plus sign, in the earlier example, we were having here 2 pills. There were 2 pills. If I clicked on the plus sign of year, there were 2 pills. One was year, and here it was showing me the quarter. Now, what is happening here in the continuous field, that year pill is getting converted to the quarter pill. Yeah, because I clicked here plus sign in the year pill, it converted to quarter. And now you see here we are getting a continuous line. Yeah, we are not getting 4 lines here for 4 different quarters. We are having only one line, continuous line. If I put my pointer here, it is showing me quarter 1 2021 sales is 75,972. This is quarter 2, quarter 3, quarter 4 of 2021. Then here it comes quarter 1 2022, 2023, quarter 2 22, quarter 3 22, and quarter 4 22. So whenever you want to have a continuous line in your line chart, then you please convert this, whatever the date field you are having, you convert it into a continuous field. Then only you'll be getting the continuous line, otherwise not. Okay. So currently we are at the quarter. Now in the front of quarter also we have here plus sign. So I click here plus sign. So now we are at the month level. So see, now here we are having again a continuous line. We are not having separate lines. It starts from January 2021 and it ends over here at December 2024. Yeah, so this is a continuous line and we are at the month level. Again, if I click on the month, this plus sign, so it is showing me the week. Yeah, here it is showing me the week. And then if I click on the week plus sign, it will take me to the last level of hierarchy, that is known as day. Now remember that this is a continuous line. This is not a broken line. In the discrete area, we were able to see the broken line, but here this is not broken. It starts from here. Let's say it is 4th of January 2021 and it ends at 30th of December 2024. Yeah. So this is a continuous line and we are at the day level, the lowest level of hierarchy. So see, these concepts are more relevant in the case of line chart. Yeah, because we are taking care of the we are taking the date field. That's why. Okay. And remember the color. Color is very, very important here. Yeah, even a layman can tell you that whether this, if the color is green, then it is continuous. Yeah, so you have to remember this point. Okay, so here we are at the lowest level of hierarchy, that is the day level. Now see, from day level, I want to go back to the year level, let's say. So here, in the case of continuous fill, I cannot directly go to the year level, because here I don't have that option, because see, earlier we were having here various fill, and if I clicked on the plus minus sign, if I clicked on the minus sign in year fill, I was coming to the year level. But here I cannot go directly from day to year. What I have to do, I have to click the drop down here in the day order date. If I click the drop down, in the drop down, I can see here that I'm at the day level. Now, if I want to go back to the year level, what I have to do, I have to click this one option, not this year, this year. Okay, so I click this year, and now I'm again at the year level. Again, if I click this plus sign, from year I come to quarter, from quarter I come to month, from month I come to week, and then week I come to day. Again, from day, if I want to go back to year, I have to click the drop down, and I select this year, and I'm at the year level. So this is how you are coming to the year level if the date field is a continuous field. Okay, and again, if you want to convert this continuous field to discrete field, I have to click this drop down, and I have to click now this year, the first year here. If I click this year, you see the color, now it is blue color. Now if I click on the plus sign of year, it is showing me another level, quarter. If I click on plus sign of quarter, it is showing me month. If I click on plus sign of month, it is showing me day level. So now this is a discrete field again. Okay, so just take care of this concept here, discrete and continuous line chart. Now let us do one thing. I'll convert back this discrete date field into continuous date field. Okay, so now I've changed the color here. I've converted to continuous date field. Now let us put here the label. Okay, labels also I want to show you something here. So in the label, I will drop here. See, I have taken here what? Sales. Okay, sales. So I will drop the sales. I'll put it here in the label. So see, you can see that these are my sales, sum of sales. Yeah, just drop the sales in the label, and the labels are ready. Okay. So for each year, I'm able to see the total sales. Now I go to the quarter level. Okay, from year I go to the quarter level. So I click the plus sign here. Now this is a quarter level. Okay, similarly, if I click on the month level, you see the month level say labels, and then this is the day level. Okay, or week level, sorry. Again, I come back to the quarter level. Okay, I can click on the drop down. I can directly come to this quarter. Now, in this label, I want to show you something. This is very, very important. So if I click here, this label, see, currently I'm at the quarter level. Remember this point. I'm at the quarter level, and I've made the order date this continuous. Okay, my order date is continuous. So if I click on this label, this button here, label, when I click on it, in the label, I can change here the text here. Okay, I can change here the text. If I click on these three dots in the text, it is showing me sum of sales. If I click on the three dots, then it will open up this window. Now in this window, what I can do, I can increase the value font. Okay, I can change the font type here. I can change the font value. Yeah, let me select here 10. Let me select first of all this one. You have to select this sum of sales. I have to click the drop down. I have to click here 11. Okay, 11. Let me change the font. Yeah, let's say I go for Sitka, small, something like that. I make it bold. I give some color here. Okay. I take some good color here. Yeah. Okay, and I go for apply. Okay, you see here, now the things have changed. Yeah. So remember that I have to click the three dots here. I have to select, remember this thing, I have to select this sum of sales, and then I have to adjust all these things, whatever I want to do. Okay. But first of all, you have to select everything, this one, the title, and then you can adjust things in, and then you can click on apply. Okay. And now the fonts are now bigger. I've given some orange color and so on. I can also do it from here, font, if I want to adjust. Then I can go for alignment. Now see alignment here, it will work. Alignment, if I click here, you see alignment is like this, or like this, or straight. Okay. I can also bottom, then middle, and then top. Just now top is looking better according to me. Yeah. So I can adjust the alignment here. Okay. Now here, this concept is important. This one, that in the label, this marks to label, this area where we are having here 6 options, this is important. Yeah. So in the marks to label, what we have here, option all, mean oblique max, line ends, selected, highlighted, most recent. Now just now you can see that all these labels are shown here. Yeah, all the labels are shown. There are total 16 labels because we are having here 16 points. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 labels are over here. Now suppose I don't want to see so many labels. What I can do, I can click on this label button. So suppose if I want to see only the minimum and maximum, I'm interested in only in the which is the minimum value, which is the maximum value. So in that case, in the marks to label, I have to click this option, mean oblique max. Yeah. So if I click on mean oblique max, so I can see here that this is the minimum value, 70,392, and this is the maximum value in all the quarters. Yeah. So I'm interested in only in this point. Yeah. Because see what happens that when you are having more labels, you get confused. So you want to see here minimum value and maximum value. That is what you get over here in the label. Yeah. So in the label, we are having mean oblique max. Then we have here line ends. Let us see what is this line ends. If I click on this line ends, then what it shows here, it shows me the starting value and the ending value. Yeah. So where the line are ending, there only I see the value. Yeah. So sometimes you may require these kind of label. You want to see the starting value, you want to see the ending value of the line chart. So this is what we mean by the line ends. Then we have here concept known as selected. Let us see what it is selected. So if I click on selected, yeah, just click on selected. So see, just now you don't see anything. There is no label. When you click on selected, you don't see any label. Now, let's say I want to see this label of 2021 quarter 4. So if I click this one, see, if I click this one, I can see the label. If I click this one, I see the label over here. So this is what we mean by selected. Yeah, whichever point you want to see the label, you can click on it and that label will appear. Yeah, so unnecessary, you are not getting confused over here with so many labels. So this is what we mean by selected. Okay, so label, we have gone for selected. Then comes here highlighted. Now what is this highlighted? Let us click on highlighted. I click on here highlighted. So see in highlighted what we do, suppose if I want to see here this label, this point and this point, the value of this point and this point. So what I do here in the highlighted, I create with the help of my mouse, I create this kind of box. Okay, I create this kind of box and I select these 2 points. Yeah, again I'm repeating. I select with my mouse, I create this kind of box and I select these 2 points and then I release my mouse button. When I release my mouse button, I can see the values of these 2 points which I've already highlighted. So whichever area I highlight, in that area, whichever points are available, only the labels of those points will be highlighted. Let me show you again. if I click here over here, and if I select these kind of points, then here you can see only these labels are highlighted. The other labels are not shown over here. Yeah, I can also create like this. Okay. So with the help of our mouse, you have to select the points. That is what we mean by highlighted. And the selected means if I click on this, yeah, if I see if I have if though it is highlighted, but I can also click one point. So highlighted and selected, they are almost like same, but little bit the option is that in case of highlighted, let me try with selected also. Selected, yeah, in selected also I can create these kind of thing. Okay, but normally selected is this point. Okay, whichever point I select, it will show me the value. That is what we mean generally. We mean by selected. And highlighted means whatever the points we highlight like this, only though their values will be shown over here. Okay, so these are the 5 methods over here, and the last method here is most recent. If I click on most recent, then it will show me the last value, because last value is the most recent value. That's very clear. Okay, so most recent means this quarter 4 2024 is the last value that we are having, so only that value will get highlighted. That is what we mean by most recent. Yeah. So this is all about your labels. Still we'll be talking more about the labels, don't worry. Yeah, and in this label, if I click it, and there is one first tick mark over here which says show mark labels. If I remove this tick mark, then all the labels are gone. Suppose if I select here all, see, I selected here all, and if I tick mark this thing, then all the labels are shown. But if I remove this tick mark, all labels are gone. Okay, so this is one label area. Now you have another button over here which is known as here T, this one. Okay, on the top also you have the T, that is also for label. So if I click on this small button T, again the label will come up here. Yeah, if I click here again, the labels are gone. Again, if I click this T, my labels are back. And now if I want to modify anything, then I have to come over here. I have to come over here to this T label, and now I can modify the things over here. Yeah, but this is also a method where, suppose, see, let me show you. If I remove this sum of sales here in the label, I remove this sum of sales, and now let me try here. If I click this T button, so see, if I click this T button, see, I have not put here anything in the label, but although I have clicked here the T button, it is showing me all the labels without putting anything in the label. Yeah, so that is another advantage over here of this small button here. Yeah, if I click on this small button again, all the labels are gone. Yeah, but better I would say that you drop the field on the label. That's the better I would say suggestion. Okay, so put the field onto the label, and the labels will be shown like this. Okay, so this is all about your label. We can also go for here. See, there is one, when we are creating a line chart, then we have one separate button here known as path. Okay, so if I click on this path, in the path I am having these 3 different paths. That is, one was known as linear, second one is known as step, and third one is known as jump. If I click on step here, so see, now it is showing in step. If I click on jump, it will be shown like this. Yeah, so these are various line types. This is a normal line type, then jump, and then step, and then jump. Then I can also select this line like continuous line, solid line, dashed line, dotted line. Yeah, I can have these kind of options here. I have selected here this path. Okay, path button. There I see these options here. Yeah. So let us give the sheet name here as line chart. Now, after the line chart, Let me show you one more option here that is known as tooltip. Okay, we have seen color, we have seen size, we have seen label, we have seen path also, and now we are focusing on the tooltip. And then later on, we'll also talk about the details here. Yeah, details button. But let us focus on the tooltip. Now, see what is the tooltip here? This is your tooltip, this white box, as you can see. Now I can also customize the tooltip. Yeah, I can customize this tooltip. So what I'll do here, I will click on this tooltip, this button. And if I click on the tooltip button, I get this dialog box known as edit tooltip. Okay, just click on this button, tooltip, and this edit tooltip dialog box will open up. Now here I can modify the things. See how it is written here, quarter of order date. This is the title, and then here it is showing me the quarter. Then it is showing me the title sales, and then it is showing me the sum of sales here. So I can modify here. I can make the title, this tooltip, little bit bigger. Okay. I can also make everything bigger here. Let's say 12. Okay. Then I can give this color over here. Let's say this quarter of order date. I can give this one, not the title, but this one, quarter order date. I can give here some green color, and this sum of sales, I'll give here something like blue color. Okay, so I can modify these things. Plus here, I can also add some extra field here. Let's say just now what it is showing me here, order date, quarter of order date and sales. But let's say I want to also see here the profit. Though I have not used here profit in this chart, but I want to also highlight the profit value in this tooltip. So that is also possible. So what I do here, after this sales and the sum of sales, I press enter, and now here I can write down profit. Yeah, it will show me in other color. Let me put it in black color. Okay, or gray color here. I don't know which color they have used here. Okay, let me take here everything black. Okay, this also black. The title I'm talking about. Okay, so I've taken here profit. Now in the profit, what I do here, I want to see here the sum of profit. Yeah, now this is the title. This is the additional data that I want to show it to my my colleague. Okay, so profit, title. Now here I can go to this insert. Okay, insert. Now in the insert, you can see that I can add here the data source name, data update time, sheet name, workbook name. See, let me put here sheet. Suppose if I remove this profit, and let me come to this insert, and in the insert I select here sheet name. What is my sheet name here? Sheet name is line chart. If I want to put it in the tooltip also, I can go over here, insert, I click on sheet name. So sheet name will come up. I press enter. In the next line, I want to see the workbook name. I write down the workbook name. Again, I press enter. Yeah, and I can also put my full name, username, etc. Yeah. Now here, what I want to do, I want to put here profit. Okay, I want to see here put the profit, and here I want to see the sum of profit. But just now you can see that I am not have. If I go to the insert, I am not having here profit column here. I'm having only two options here, quarter and sum of sales. But let me click here all fields. Let me click on all fields. Let us see what happens. Okay, all fields will show me everything. So I don't want to go for all fields. Yeah, I want to put here only sum of profit. So what we'll do, let us write down here profit, double quote. I click on OK button just now. I click on OK button. If I put my pointer here, you see here, when I put my pointer, it is showing me quarter of order date is this much, sales is this much. Now, then it is showing me the line chart. That's the sheet name. Then it is showing me day 3 types of charts, which is the workbook name, my file name. and then it is showing me profit double dot. Yeah, profit and colon. That's all. It is not showing me any value. Now, if I want to see here in the tooltip profit, what I have to do, I have to drag this profit. Yeah, this profit field, I have to drag it and I have to drop it on the tooltip. Yeah, I have to drop it on the tooltip, not the label. So I drag the profit, I put it on the tooltip. So now here you can see that sum of profit is dropped on the tooltip. This is the tooltip icon. Yeah. So this is important step. Then I go to the tooltip again. I click on the tooltip. So here I want to see the profit value. So now I've already written the title profit. Let me make it black color. Okay, and now I want to see here sum of profit. Just like sum of sales, I want to see here sum of profit. So what I have to do, I have to go to the insert, and now in the insert button, insert drop down, I can now see here sum of profit. Initially it was not there. So we drop the profit and we put it into the tooltip. So now I'm able to see this sum of profit in the insert. So I click here sum of profit, and now automatically the sum of profit will come up. I can give some color here if you want. Okay, so this is how you are bringing the field which you have not used in this visualization. I have never used any sum of profit in this visualization, but still I want to show to my users. So profit, sum of profit, I click on OK button, and now if I put my pointer here, you can see that it is showing me the profit. The tooltip profit is currently, it is showing me 16,880. Okay, so you can do lot many customization in the tooltip also. That was my point here. Yeah, these are all the customization here. Just click on this tooltip button and then you can adjust many things here. Yeah, you can also click here. Let's just show tooltip. Suppose if you don't want to see the tooltip, then let us remove this tick mark. I remove this tick mark, show tooltips. Click on OK button. And see now if I put my pointer here, it is not showing me the tooltip. If you want to remove that tooltip, you can also remove it. Yeah, by removing this tick mark. Again, if you want to see it, you can put the tick mark. Then what it says here, responsive, show tooltips instantly. Instead of show tooltip instantly, I can click the drop down and we can also go for here on hover. If I click on hover, let us select this option on hover, show tooltips on hover. I click on OK button. So see, when I put my pointer here, hover, then only it opens up. The earlier one was more responsive, but here now, if I hover on a particular point, then only it comes up. Okay, so you can play with these options here. Okay, clear? Tooltips, options, and any question to line chart, let me know. Okay, so line chart is ready now. Now let me show you two kind of maps here. Yeah, the basic maps. We are having here field map. There's a concept known as field map, and another map is known as symbol map. Okay, so here in the show me, if you click on the show me here on the top right corner, then in the show me, you can see that these are the two maps here. Yeah, these are the two maps here. So the first map here, it is known as symbol map. Yeah, just see the name over here. So the first map is known as symbol map. For symbol map, we require here one geographical field. So it is written over here. Just check over here what is written. When you put your pointer on the symbol map, in the symbol map, you require one geographical field, 0 or more dimensions. Now see, geographical field is already a dimension. Then if you want, you can also use one more dimension, and you may require no measure or maximum 2 measure. Okay, so if you don't put any measure also, then also it is fine. But for field map or symbol map, you require minimum one geographical field, minimum. Okay, if you don't put any measure, then also it is fine. So this is the first map here. It is known as symbol map. And the second one here, when you put on the pointer on the second map, it says here map. But what is second map is known as field map. FILLED field map. So remember these two words, symbol map, field map. Okay. So let us click on the new sheet here, create a new sheet. Let us write down here symbol map. Okay, first of all, we'll create a symbol map. So as we have seen that for symbol map or field map also, we require one geographical field minimum. So now here, which are the geographical field? Can you tell me here which are the geographical field in our data set? You can see the geographical field by the icons. Okay, when you see the icons, you'll be able to see it. Region is not a geographical field. Let me clarify this point, Srinivas. Region is not a geographical field. Just check the icon here. It is ABC. Yeah. See, the geographical fields are these fields which are having this globe icon. So postal code, you can see that it's having a globe icon. Then country oblique region, it is having. Now see this country oblique region. Now definitely here we should be writing better. We write down here. We can also write down here country. Okay, better we write down here country, not the country oblique region. Let me remove this point. Okay. So country. Okay. If you are having country oblique region, you can right click here and you can rename. Okay. When you rename, you can just remove that region. Just keep here only country so that you are not getting confused here. Yeah. So country, you can see that it's having a globe icon. This is a geographical field. City is also having a globe icon. Again, a geographical field. And then you are having here the state. Yeah. State oblique province. In case of Canada, they are having provinces. In other countries, they are having states. Yeah. So state oblique province, that's also having a geographical field. Yeah. So there are here 4 geographical fields: country, state, city, and postal code. Region here, unfortunately, it is not a geographical field. Okay. So now what we'll do, that if I want to create here a symbol map, then now see in this case our data set is from US. So we are having different states sales figures and different states profit figures. So we'll be focusing on the state here, this field. Okay. Suppose if we are having data of various countries, then we can definitely select this country also as the one of the geographical field for creating the map. But I'll go for here state oblique province, and then I want to select here, let's say, sales. Okay, sales. So what I do, again the same method. If I want to select here 2 fields, one dimension and one measure, I have to press the control button, and then I select here state oblique province, and I select here, let's say, sales. Okay, by pressing the control button. So 2 fields are ready, state oblique province and then sales. And once you select this one geographical field and one measure, you can see here automatically these 2 maps are active. Initially it was not active, but now these 2 maps are active. So what we do, we click this first map here, which is known as symbol map. Yeah, so I click on this symbol map, and when I click on this symbol map, what happens? I'm able to see the overall world map, but I'm not able to see any data here. See, just click on the first button here after selecting the country oblique province and sales, and then here we are able to see like this only. Anybody is able to see the map? I think so. Those people who are in US, yeah, you are able to see the map and the data. Am I correct? Yeah, I think so. If I'm not wrong, then Nisha, are you there? Nisha, you are from US, and anybody who is from US, you can let me know. Yeah, that you are able to see the map or not. But those who are from other parts of those who are living in other countries except US, you'll not be able to see anything. And what you are able to see here below, just like me, you are able to see here 59 unknown. Am I correct? Yeah, those people who are in India, let's say, are you able to see anything over here? Or you are able to see like 59 unknown, just like me? And also maybe those people who are in, let's say, Africa or other countries, yeah, except US, same as yours. Okay. So this is the issue. Now, what is this 59 unknown? And why you are getting this 59 unknown? Yeah. The problem is here that, see, I'm in Germany and I'm using the data of US. So currently my local setting is Germany. Yeah. And if I'm using the data of US, then I'll be getting these kind of unknown. If you are in India, or if you are in, let's say, in Africa, or if you are in even in, let's say, uh, uh, Asia, okay, you are using the data of US and you'll be getting this kind of error, 59 unknown, yeah, because of your local setting. So now what you have to do, very, very important part now comes over here, that once you have created the map, but you are not able to see any data and you are able to see these kind of unknown, then what you have to do, you have to go to this map tab over here. You can see on the top area, we are having the map tab here. So there is a map tab over here. In the map tab, if you click the map tab, then you are having here one of the option known as edit locations. Edit locations in the map tab. So click on edit locations. In the edit locations, it will open up this dialog box. It says here edit locations. Now here you can see that in my case, country oblique region is selected here as Germany because that's my local setting. If you are in India, it will show you here country oblique region India. Yeah, or if you are in Africa, it will show you here Africa or your own country. Sorry, not Africa. Africa is a continent, but your own country here. So what I have to do here, I have to adjust this thing. Yeah, I want to see the data of US, so I have to click this drop down in this country oblique region. I click the drop down. When I click the drop down, I'm having here various options: none, fixed, and from field. Yeah. If I click on none, it doesn't make any sense here. I have to click on fixed just now. Fixed. Now in my case, fixed is Germany by default. What I have to do? I have to, in the fixed Germany, I click the drop down and now I select here, I search here United. So I select here United States. Okay. I don't select this one, United States, minor outlying islands. I'm not that much sure about this option, but I go for the United States. So see, now in my case, instead of fixed, it is United States. Okay, now one more thing here, it is happening here. You see here, when I select here United States, see what is happening here? Here we are having also the data of Canada that I forgot. So see, we are having here Alberta, British Columbia, Manitoba. These are all the provinces of Canada. So whenever I'm selecting here country oblique region United States, I fixed my location to United States, then it is not able to identify the provinces of the Canada because I have fixed my country equal to United States. So see, this is everywhere it is showing me here unrecognized, unrecognized. Now if I go below unrecognized, then it is showing me here Alabama. So here also it is showing me matching location is Alabama, Arizona, Arizona, Arkansas, Arkansas. This is fine. For US it is fine, but for Canada it is not recognizing. So now what is the solution? If I if I fix here instead of United States, if I fix here instead of United States, if I fix here Canada, suppose. Okay, if I click here Canada, okay, if I click here Canada, fixed. Now you see here all these states of US are unrecognized. Okay, all the US states are unrecognized, and if I go down, then it is showing me Alberta, Alberta, British Columbia, British Columbia, Manitoba, Manitoba. So now I am able to match the provinces of Canada, but now I'm not able to match the states of US. So you will definitely have these kind of situation. So what you can do now, you can go to this country oblique region, and instead of fixed, yeah, instead of fixing any country, you have to go to from field. From field. Okay, if you are having data of many countries, then don't go for the fixed option, go for the from field option. And from the field, what field we are taking here? Country field. Yeah, because the data is related to different countries, so I select here country field. Yeah, so from field country. Okay, and now you can see here it is matching Canada with Canada, United States with United States. If I go to state oblique province, yeah, see there are two options, two panels here. Country oblique region, it is matching. If I go to state oblique province, here also it is matching. Everything is matching. You see, Alabama, Alabama, Alberta, Alberta, Arizona, Arizona. Now you are not getting here unrecognized. Okay. So remember this portion that when you are having only the data of one country, then you can select here fixed. Suppose if you are in India and if you are also using the data of India, then you will never have this issue of unknown. Remember this point. But you are in India and you are using the data of, let's say, Germany. Then you have to change this thing. You have to fix fixed equal to Germany. But if you are having data of various countries, including India, then you have to go for this option known as from field. And in the field, you have to select here country. Yeah, because in your data set also you'll be having a country column. Yeah, you'll be having country column, city column, state column. You have to select here from country. And then it will match up each and every data like this. Okay. And now once the data is matching, then you click on this OK button. OK button. And now you can see it is showing me the data of US. And see, there are also these small points here. See that the sales data of Canada is very, very less. So there is a dot. If I put my pointer on British Columbia, then the sales is 2,763. If it is Alberta, it is 11,000 something. Yeah. So the dots are there in Canada also. Quebec also it is there. Ontario is there, and plus all the states of US. So this is a symbol map. Yeah, this is a symbol map. Why it is a symbol map? Because it is using a symbol here. Yeah, here it is using the symbol as circle. Yeah, and here this California is having a bigger circle. If you want to increase the circle, let's say you are not able to see this Alberta circle or this Canada, this Saskatchewan circle, what you can do, you can go to this size button, click on the size, and you can increase this circle. You see here, I have increased this size of the circle by going to the size, and now at least I can see this thing. And still, if you want to make it bigger, you can also make it bigger like this. Okay. So see, now I can see British Columbia, Alberta, Saskatchewan. Yeah, and here also I can see many circles here. I have to go to the size. So this is what is known as symbol map with this one. So I think so symbol map, I hope that you are all clear. Yeah. Now here we are having the, let's say the, yeah, one kind of a legend that what is the size and what it is highlighting here. Now see these kind of legends, suppose it doesn't make any sense. Yeah. Because if you put your pointer on this circle, you'll be able to see the value. Yeah. Here it is showing you the minimum value of the sales, which is 132 in one of the province. Maybe I think so. Yeah, it is Saskatchewan here. And the highest value is 457,688. Yeah, that is this one, California. Yeah, it is having the biggest circle. So it is having the highest sales. So I would say that suppose if you don't require these kind of, let's say the legend, what you can do, you can click on this drop down here in the sum of sales, click on the drop down, and in the drop down we are having this option known as hide card. Hide card. Okay, click the drop down and click on hide card. So see, now you are getting here more space. Yeah, and that kind of legend, it was not having any sense here. Yeah, so just hide the card and it will go away. Also, I would like to show you here in let's say in this stake column chart or this pie chart also. If I in the pie chart and stake column chart, I can see here this legend. Okay, now see this legend is occupying a space here. Yeah, because if you see this below area, this is totally blank. So it is just a wastage of space here. Yeah. Why this is blank? Because here we are having this legend. So what we can do here, instead of putting this legend over here, by default the legend will come over here in Tableau. But I can bring this legend in this area. Where? Here. Okay, because see, this is also blank. Yeah. So I will bring this legend from this area to this area. Okay. So what we have to do, we have to simply select this legend. Okay. Let's say when I put my pointer over here. Yeah. Sorry. Start my camera. Yeah. So when I put my pointer over here on this legend, then I can drag it. You see here, I'm dragging, and then I'm dropping over here like this. I drop over here, and you see here, now I'm able to see the legend here. And once my legend comes over here, now this space is occupied. Okay. Now there is no wastage of space here. Again, I'm repeating. Yeah. What we do, that this was over here. Okay. So what I do, I drag this legend and I bring it over here below the marks card, and now this legend is over here. So I'm able to see the legend also, and plus I'm able to get here more space in the chart. Yeah. So this also you can remember here. Okay. And for symbol map, there was here one kind of a small legend, but that I did not require, so I had hidden that card. Yeah. So in between also, let us save this file. Okay. Save it. File, save it. Save. So now this is the symbol map. Now let us go to the next map for here. We go to the next sheet here, and here we will be creating the field map. Okay. So for field map also, we'll require a one geo dimension and one measure. Minimum one geographical dimension we require. But if we want to see sales or profit, then we also require the the measure over here. So for this second map here, what we require the state. Okay, so I select here the state, and now I press the control button as usual, and now let us select here profit. So for field map, I want to use here the profit. So state, and then I press the control button, I select the profit. So two fields are selected here, state and profit, and then I click this second map here, not the first map, second map. If I click on the second map and I remove this close show me. Yeah. So here, what is happening? It is showing me the data of Canada, as you can see, but now it is showing me here 49 unknown. So it is not showing me any data of US. If this is the situation in your case also, you know the things, what we have to do. Yeah. In my case, it is showing me 49 unknown. Yeah. I can also click this 49 unknown. If I want to remove this 49 unknown, I can click on this 49 unknown. When I click it, 49 unknown, I get here this panel. Yeah. Just click on the 49 unknown, you get this panel. In the panel, you click this edit locations. In the edit locations, what is my issue here? My country oblique region is Canada. Yeah. I don't want to keep it here Canada. I click the drop down. Instead of fix Canada, I go for here from field. From field, and I select here country. Okay. So from field is country here. And now everything is matched. Okay. So select here from field country. I click on OK button. And now you can see here the data of US and Canada. Okay. Yeah, now it is there. Okay, so now I'm able to see this is a field map. Why it is field map? Why it is known as field map? Because here this sales, the profit, it is shown by the colors, and these colors are filled here. Okay, they are filled over here. So that is known as field map. While in case of symbol map, I'm able to see the symbol only. Yeah, with the help of the symbol, I'm able to know whether the sales is high or low. Okay, but with the field map, it is showing me with the help of the colors. Okay, so here you can see that California is having the dark blue color. So California is having the highest sales. Yeah, sorry, highest profit. Okay, then we are having here New York, which is having the second best profit. Okay, then you can see the different colors of or the shades of blue color, and this orange color, the dark orange color, let's say this Texas, if you see if you put the pointer on Texas, it is showing you here profit is equal to minus 25,729. It is showing you minus. So there is a loss over here. So that's why when there is a loss is highlighted by the orange color. Yeah. And here this is your legend on the top right corner. Let me bring this legend over here. You see, I brought the legend over here, and here it is showing me the maximum value and the minimum value. The minimum value is minus 25,729. That is for this Texas, and the maximum value is 76,381. That is for California. Okay. So here it is showing me the dark orange color. Then slowly the dark orange color become light orange, almost white, and then it starts with blue color, and then it finally becomes the dark blue color. Yeah. So with the help of these shades of color, I can see that which state is having the higher profit and which is having the lower profit. This is known as field map. Now, one thing which I forgot in this symbol map. Yeah, please come to the symbol map here, or let us give the sheet name first of all here. Sheet 7. I give the sheet name as field map. Okay, sheet 7 is field map. Okay, so give the sheet name here. And let us come back to this symbol map. In symbol map, I have to show you one concept here. See here, what is the shape of this symbol? It is circle. Okay. Now suppose if I don't like circle, I want to see here, let's say rectangle, or let's say triangle, suppose. Okay. I'm not happy with this circle symbol. So if I want to convert this circle into any other shape, what I have to do, I have to come to this area. Okay, this area here, where it is written here automatic. Okay, so in the currently the automatic, it is showing me this. This is also known as circle chart because it is using the circle. So if I click on this drop down here, automatic, instead of circle, if I want to see here square, I can select here drop down and I can select here square. So see, now it is square. Okay, symbol is square. But suppose if I want to convert it into triangle, suppose. So if I want to convert this symbol into triangle, then I have to click here the drop down, and the drop down, see, I cannot see here triangle. I can see here square and circle only. Yeah, there is no triangle here. But if I want to go for triangle here, then I'm having one option here known as shape. Shape, okay. So if I click on this shape, yeah, just click on the shape here, and now you are having one additional button known as shape. Yeah, click here shape, and you are having one additional button known as shape. Yeah, so now you can see that this is currently circle. This is a different kind of circle. But if you don't like the circle, if you want to have the triangle, you can click here the shape button. Yeah, click on the shape button, and now you can select here, let's say this filled triangle or empty triangle. Suppose if I select here filled triangle, this is what I see here. Yeah, or this is rhombus, I think so. Rhombus. Yeah, I can go for here plus sign or multiplication sign, star. These are some of the shapes. Yeah, if I want to have more shapes, I can click here this more shapes. If I click on more shape, then I'm having this dialog box. Yeah, that is edit shape. In the shape also, I'm having here shape palette. Yeah, just click here on the more shapes. This panel will come up. In the panel, you are having here shape palette. I click the drop down. In the drop down, I'm having here default, field, arrows, bar, bug tracking, gender, KPI, proportions, ratings, thin arrows, weather. If I click here field, then these are all the field shapes. Yeah, likewise here, these are the default, and we are having different kind of arrows. Okay, so here you can change these things. Okay, So this is how we are changing the shape of the symbol map. Yeah. Okay, so coming back to the field map here. So this is the field map. Yeah, field map also it is very looking good. Yeah. Now let us focus on these buttons over here. These buttons. Okay. So we are having here the search button, the first one here. If I click on the search button, I can search here anything. Let's say I search here Texas. Okay, I search here Texas. So now it is showing me here Texas, United States, or Texas City, Texas, or Texas County, or Texas County. Also, there are two Texas County in Missouri and Oklahoma. Yeah, suppose if I want to go for the Texas state, I select here Texas state, and now it is showing me only the Texas state. It is highlighting the Texas state here. Okay, if I want to go back to the original map, then here I am having one button here. You can see this pin button. If I click this pin button, I'm going to the original map. Yeah, just click the pin button here. If I search here, let's say New York. So now it is asking me whether it is New York as a state or New York as a city. So if I click on New York, then here this is the New York. Okay. And if I click on again on this pin button here, I'm going back to the original map. Yeah, so this is the search button. Then this is plus or minus, that is zoom in, zoom out. Okay, zoom in. If I click on minus sign, yeah, that's very clear. And if I zoom in too much, and if I want to go back to the original map, I have to click the same button, this pin button, and my original map is back. Okay, so this is that button for coming back to the original map. Then we are having here this kind of button, the last button. In this last button, we are having here zoom area. Then we are having here pan or pan. Then we are having here rectangular selection, radial selection, and lasso selection. Yeah, these options here. So if I click on this zoom area, if I click on zoom area, so see now this zoom lens is coming up. With the zoom lens, I can click on this thing. Okay, I can click on, let's say, this Montana. It will zoom in, still zoom in, something like this. Okay. So this is what we mean by this zoom lens here. If I want to go back, I have to click here this pin icon. I'm back over here. Yeah. Then if I want to see, currently I'm having the data of US and Canada, but let us assume that we are having the data of various countries. So suppose if I want to move between the countries in the map. So what I have to do, I have to click on this arrow and I have to click this option here that is known as pan. If I click this pan option, now I can move freely here. Okay, I can go to this South America. Suppose if I'm having the data of South America, I go to South America, Africa, yeah, Europe. I can move anywhere here. I can go to India, here, Asia. Yeah, I can go anywhere here. So that is what is this pan button here. These four arrows in four directions. Okay. And if I want to go back to my original, reset my map, I have to click again the pin icon. I'm back over here. Okay. Then we are having these three buttons here, which is known as selection button. Rectangular selection, radial selection, and lasso selection. Now, what is this selection all about? So, let's say I want to select here the states which are part of the western region. Okay. Let's say I want to select here California, Nevada, and Oregon and Idaho. I want to select here only 4 states here out of all these 50 states. So what I can do, I can go to this arrow and I can click here in the arrow. I will click here this rectangular selection. Okay, first of all, we'll go for the rectangular selection. I click it. And now once this rectangular selection is selected, then what I do, I create this kind of rectangle with my mouse. Okay, I create this kind of rectangle and then I select here all the 4 states. So see, when I select all the 4 states, then only these 4 states are getting highlighted. Again, I'm repeating, I'm going to this button, I'm clicking this rectangular selection, and then if I want to select some few states here in the western region, with the help of my mouse, I create this kind of rectangle and I can select whichever state I want to select. Yeah. So I select here these 4 states and now only these 4 states are getting highlighted. Okay, with the help of the rectangular selection. Similarly, I can also go for here radial selection. So instead of rectangular, if I click on radial selection and with the help of my mouse, now it will create a circle. Yeah, so whichever state is coming under that circle, it will get highlighted. Yeah, these are getting highlighted and this is known as a radial selection. I can also click over here like this and whatever the states are selected within the circle, all those states will get selected here. Okay, so this is known as radial selection. Now, what is my requirement here? That I want to select here, let's say California. I want to select here Nevada and I want to select here Idaho. Okay, I want to select here only these 3 states, California, Nevada, and Idaho. I don't want to select here Oregon. Sorry, this is, yeah, Oregon. Okay, I want to select here only these 3 states. So if I go to this button and if I click here rectangular selection, so if I create here these kind of rectangle, what is the problem here? That with the help of the rectangular selection, by default, Oregon is also getting selected here. Yeah, because I don't have that control. Yeah. So when I'm selecting the California, Nevada, and Idaho, automatically Oregon is also selected. That is with the the rectangular selection. Now if I go for radial selection, circle. Okay, so if I create here one circle and if I make it bigger, you see here with the help of circle, I'm also able to select here Washington and Utah, so Utah and then Arizona. I want to select only the 3 states, but along with the 3 states, the other 4 states are also getting selected. So that is the problem with the rectangular selection and radial selection. Now we are having the third option, which is known as lasso selection. This is a great option. So instead of radial selection, if I click here this lasso selection, now you see the effect. Okay, first of all, I click over here. Now you see I want to select here California, Nevada, and Idaho. So I've selected here lasso selection and now I select like this with the help of my mouse. I select like this. You see here only these 3 states are selected. I'm again showing you. Okay. Let me show you here with the help of lasso selection. I select here, I start with California with the help of my mouse and then I select here Nevada and then I select here Idaho. And only these 3 states are selected with the help of lasso selection. See, Oregon is not selected, this Utah is not selected, Arizona is not selected. So that is the advantage that you are getting here with the lasso selection. If you are having these kind of typical selection, I would say. Yeah. If you want to select here, let's say California, Nevada, Idaho, and Montana, that also it is possible. Maybe, or we can do some kind of special selection like this, you see. You see, I'm able to select only these 4 states. No other states are selected here. California, Nevada, Idaho, and Montana. So all this is possible with the help of lasso selection. Remember this point. So we have taken here all these options. Yeah. Now suppose if you don't want to have some of these options here, let's say, yeah, by default all these options will be shown here. Yeah, zoom in, zoom out, then this search option, this fixed map, and these all these options here. But if you want to remove some of these options, then what you can do, you can go to this map again, map tab, click on the map tab, and the map tab you are having here map options. The last option is map options. So go to map tab and you click on here map options. In the map options, you get here these options here. Show map search. This is your map search here. If you don't want to see this thing, you can remove this tick mark. When you remove the tick mark, the map search is gone. If you tick mark again, the map search is back. Yeah. Then here it says show layer control. Here the layer control, I'll be showing it later on because we are having a separate session on the maps where I'll be talking in more details about the other options in maps. There we'll be talking about this layer control. Then here it says show view toolbar. See, if I remove this view toolbar, then you can see that this view toolbar is gone. This lasso selection and all those things are gone. If I tick mark again, this view toolbar is back. Then what it says here, allow pan and zoom. If I remove this tick mark, yeah, if I remove this tick mark, now you can see that zoom feature plus and minus, they are gone. And also there was a pan option that is also gone. If I tick mark again, those options are back, plus or minus, and here this is the pan option. Yeah, so you can customize all these options here. Then here it says show map scale. If you see the map scale, yeah, normally you must have seen that in the case of Atlas, yeah, Atlas book, there is a scale. Yeah, so if I want to see here the map scale, so now here at the bottom area, I can see the map scale here. Okay, so this is the let me go back, map option. So this is the map scale. In the map scale also, I can go for the units. In the units, I can click the drop down, automatic, metric, or US. Now see, I am currently in Germany, so we are using the metric system. So we are having here in 1000 kilometer. Yeah, but if you are in US, you will require it in miles. So I'll select here US, metric units equal to US, and now I'm getting here the scale in miles. Yeah, if I select here metric, it will show me 1000. If I select here automatic, in my case, it will be still showing me in 1000 kilometer. Yeah, because it is taking the region here where I'm located. Yeah, so this kind of scale is also available here if you want in the map. So all these options are available here in the map and map options here. Yeah. Now one more thing here in this profit here, some profit here, you can see that we are using the orange color for showing the loss, and we are using the dark blue color for showing the profit. But suppose if you don't like this color palette, you want to use another color palette where you want to highlight the loss with red color and profit with green color, suppose. Yeah, so you don't like this color palette, so you can go to this color palette here, sum of profit. You can click the drop down, and in the drop down you can select here edit colors here. Yeah, in the sum of profit you click on edit colors, and now in the edit colors you will see here the palette. Okay, in the palette it is showing you here automatic. Instead of automatic, I can select here various shades of blue color, orange color, red color, single color. Then I can also select the combination of two colors. Then I'm having here orange blue diverging, red green diverging, green blue diverging. So let me select here red green diverging. Yeah, I select here red green diverging. So see, red color will be showing you negative, and green color will be showing you the positive values. Yeah, so here it is showing me this palette. Let me click on apply. OK. You see here now the state which is having the highest profit or more profit, they are shown in green color, and the states which are having the negative profit or loss, they are shown in red color. And this Texas is having the highest loss, so it is showing in dark red. Yeah, so this color palette I can select here. Yeah, click on the drop down, and here I go for edit colors, and now I can select here. Also here you can see that there are some shades here, but suppose if you want to fix up some shades, you want to have here 5 shades, 6 shades, then you can select here this step color. I select here step color. As soon as I select here step color, then these are the 5 steps here. Okay, so it is dark red, then it becomes light color, light red, then something like very light green color, then green color, little bit darker. If you want to have here more steps, you can increase this more steps like this. So you can also make it here 6 steps or 7 steps, you decide. You can also reverse here. See, currently dark red color is used for loss, and green color it is used for profit. But if I want to reverse it, I can click on this reversed, and when I click on reverse, now loss is shown by green color and profit is shown by red color. Normally we don't like that one, but you can also reverse it. Then here it says use full color range. If I select here use full color range, maybe this color has changed here a little bit. Yeah, I click on apply, okay, and you see now it is looking different. Yeah, now see this Texas is really dark red. Initially it was not that much dark, but now Texas is really dark red, and this California is really dark green. This is also dark green, New York. Yeah, and the other are different shades here. Okay, so this is how you can change the color palette here, and you can also adjust the things here. You can also edit the title here. Let's say this is the title. What is the title of this legend? It is sum bracket profit. If you don't like this title, you can click on the drop down. You can edit the title. Yeah, so sum bracket profit. If you don't like this one, you can write down here total profit. Total profit. I can make it bigger. I can change this thing. Yeah. So see, now it is total profit here. Now, though it is total profit, it is not showing me properly here. I think so. Now it should be showing me in. Yeah. See here, when I put this field map onto the dashboard, yeah, then I can see here the dark red, this bold and bigger color. Okay. See in the field map, when I change this total profit, the title, here it is not showing me that formatting options. Means it is not showing me the title after the formatting has been done. But if I take this map onto the dashboard, here I'm able to see the things. Because see, for me, what is important? The dashboard is important. Finally, when I'll be bringing all the visualizations together in one place, then the dashboard is important. So in the dashboard, I should be able to see all the formatting. Okay, this is what I can say here, but we'll be talking about the dashboard a little bit later. So here I can do these formatting options. Yeah. So we'll be creating here one last chart here that is known as tree map. Okay, yes. Okay, so now the same thing I'll be also able to show you in the Tableau. So in the Tableau, if I go to the show me, in the show me, I'm having this tree map here. This is my tree map. Yeah, this area, this is the chart here. So for the tree map, what I require here, it is shown below. For the tree map, I require here one or more dimensions and one or two measures. Yeah, so minimum I require one dimension and one measure, minimum. Okay, if I'm having more dimensions, more measures, that is fine, but at least I require one dimension and one measure. Yeah. So here what I'll do, that I'll be selecting, let's say, subcategory. Okay, I select subcategory, and let me select here quantity, suppose. Okay, subcategory and quantity, you can select here any other field. I select here subcategory and quantity by pressing the control button, and now you can see that my tree map is active. So I click on the tree map. Okay, I click on the tree map, and now my tree map is ready. Very easy. Okay, I have taken here subcategory and the quantity, and as you can see that in the tree map, the biggest square, so the biggest rectangle, it is shown on the top left corner. So here binders is having the highest quantity in my, yeah, and then copiers subcategory is having the lowest quantity, it is 242, and here it is 6071. Yeah, and here it is showing you various shades of blue color. This is the dark blue color, so it is having, it shows you highest or the subcategory with the highest quantity, and if it is very very light color, it means that it is having the lowest quality, say lowest quantity here. Yeah, so this is the tree map. Yeah, in tree map also, if I want to show you some label here, I can put the quantity in the label, so I can see the quantity over here. Yeah, and if I go to the label, in the label also I can here see, in the label also I'm having here, if I click the label button, I'm having here all, min, max, selected, highlighted. Yeah, the option that we have seen in the line chart. If I select here min max here, then I can see that accessories, yeah, and tables. If I select here selected is fine, but if I go for here min max, then why it is showing me here accessories and tables? Okay, it is very interesting here because accessory is not having the highest quantity, and definitely tables is not having the lowest quantity. Binders is having the highest quantity, and this is one. This is very interesting. Yeah, if I go for here min max, if I go for highlighted, then highlighted it is fine. Highlighted is working like this. Yeah, but this is interesting. I don't know whether this is an error or not. Yeah, if I go for all, it is fine. But min max, why it is showing me this thing only? You see here what I did, that here if I select here min max, then it was showing me here accessories and tables, okay, which was wrong. What I did, I go to the label, and here in the field, okay, in the field I see it was showing me automatic. Instead of automatic, I went for yeah, what it is doing here, if I here subcategory, now see, on the basis of subcategory, definitely accessories is coming first because it is starting with A, so it is showing me the quantity of accessories because in ascending order it is coming first, and the last one is tables because it's starting with T. So based on the subcategory, accessories is first and tables. So this is what we were discussing here, that when we click on this label and then when we are selecting here the field, then automatically when we select here sum of quantity, then based on the sum of quantity, binders is having the maximum value and copiers is having the minimum value. Yeah. So you likewise you can select here, but let us go for all. Yeah. So this is our tree map. Okay. So let us write down the sheet name here, tree map. Okay, and please save this file because we'll be using this file on a regular basis. So please save it.
So our chapter 1 will be about a quick introduction to Power BI. Welcome to module 1 of our Power BI full course. In this first session, we are going to build a strong foundation. Before we even touch the tool, we need to understand why Power BI exists, what problem it solves, and why companies in the current and in the future simply cannot operate efficiently without a strong analytics capability. Let me start with a simple but yet powerful observation. Every organization today is drowning in data. We have data coming from websites, CRMs, ERPs, IoT sensors, social media, finance systems, HR tools, literally hundreds of touch points. But the value of data doesn't come from the volume. It comes how quickly and intelligently teams extract insights from it. This is where Power BI becomes essential. Think of Power BI as the modern equivalent of a digital microscope. You point it at a raw, unorganized, messy data, and suddenly patterns start to appear. Trends become visible, anomalies stand out, and performance issues are revealed. Just like successful learners who improve rapidly by analyzing their mistakes and strengths, companies go faster when they analyze their data systematically. Power BI is not just a charting tool, it is a decision engine. And by the end of this course, you will understand how it allows individuals and businesses to transform raw data into insights that drive strategy, innovation, and growth. Now, let's go with the section 2 of chapter 1. What is Power BI? So let's go deeper. What exactly is Power BI? At its core, Power BI is Microsoft's business analytics platform, but that simple definition doesn't fully capture its capabilities. Power BI performs four major functions. First one, data connection. It can connect hundreds of data sources like Excel, SQL Server, APIs, cloud storage, Azure, CRM systems, Google Analytics, SharePoint, and much more. Next, we have data transformation. It includes powerful engine called Power Query that can clean, merge, shape, and prepare data through a user-friendly interface. Next is data modeling. Power BI allows you to define relationships, create DAX or data analytics expression measures, build hierarchies, and design semantic models. Data visualization and insight sharing is our next point. Finally, it enables you to present the insights using interactive visuals, dashboards, and reports. Now, here's why it matters. In traditional workflows, people often work in silos. Marketing teams prepare Excel files, finance teams use SAP or Tally exports, operations teams work on CSVs or various tools. Everyone creates dashboards independently. This leads to confusion, conflicting numbers, and zero alignment. Power BI solves this fragmentation. It creates a single version of truth. Everyone, from interns to CEOs, sees the same numbers updated in real time using the same datasets. This eliminates the guesswork, the back and forth emails, and typical who updated this file chaos. Let me give you an analogy. Think of Power BI as a GPS for business decisions. Think of Power BI as the GPS for business decisions. You provide the destination, revenue growth, and cost reduction, customer retention, and Power BI gives you the perfect route. It adapts to real-time changes, helping you make informed decisions faster. This is why companies worldwide, from startups to Fortune 500 organizations, rely on Power BI for entire decision-making ecosystem. Now, let's dive into the section 3 of module 1. Why Power BI matters in 2025, 2026, and beyond. Now, let's take a forward-looking perspective. Why is Power BI even more important in 2026 than it was in a few years ago? Three major trends explain this. Trend number 1, rise of AI-driven analytics. Power BI today integrates directly with AI tools such as Microsoft Copilot, Azure Machine Learning, and AutoML. This means users don't have to manually write formulas or DAX expressions for advanced analysis. Power BI can do a lot of things. Let's discuss a few as mentioned below. First one is suggest visuals. Copilot analyzes your dataset structure and relationships, then recommends the most effective visual formats, bar graphs, line graphs, KPI cards, based on analytical best practices. This reduces guesswork and accelerates report generation. Next is summarize pages. It automatically reads all visuals on a report page and generates a narrative summary highlighting key patterns, anomalies, and correlations. This helps stakeholders grab insights without manually interpreting each chart. Then we have creating entire dashboards. By understanding your dataset and business context, Copilot can fully generate multi-page, fully formatted dashboards. It handles layouts, visuals, interactions, and defaults, making it ideal for rapid prototyping and stakeholder previews. Up next, we have explain trends. Copilot interprets real-time series data to identify rising or falling trends, seasonal patterns, and sudden spikes. It explains the why behind the changes using natural language insights grounded in statistical signals. Next ahead, we have generate DAX calculations. Instead of writing complex formulas manually, you can describe the logic in simple English, and Copilot converts it to optimized DAX expressions or measures. This is especially useful for advanced calculations like running totals, cohort analysis, and dynamic time intelligence. This shift automatically increases productivity. Non-technical users can now perform tasks that were previously the domain of data scientists. Now let's go into the trend 2. The trend 2 is all about shift to unified data architecture, which is Microsoft Fabric. So, Microsoft Fabric is becoming the core of modern analytics architecture. Power BI now integrates seamlessly with Fabric components like Lakehouse, and Power BI can directly connect to Lakehouse tables stored in one lake, enabling unified access to structured and unstructured data without complex ETL. This improves performance, governance, and cross-team collaboration. Next is data engineering. Data engineers can prepare, clean, and transform large datasets using Fabric notebooks and pipelines, and Power BI consumes these curated datasets instantly, ensuring analysts always work with high-quality, production-ready data. Followed by that, we have Data Factory with Fabric. Data Factory scheduled pipelines move data from multiple sources into centralized storage. Power BI then reads these refreshed datasets automatically, enabling consistent automated reporting without manual intervention. Now, the next one is real-time analytics. Power BI dashboards can stream live data from Fabric real-time analytics, or also known as Custom Engine, supporting instant insights for IoT, transactions, monitoring systems, or operational dashboards where every second counts. After that, we have machine learning. Fabric's machine learning models can score data and write predictions back into tables, which Power BI reads in real time. This enables AI-driven dashboards such as churn prediction, demand forecasting, and anomaly detection without leaving the Fabric ecosystem. This means Power BI is no longer just a visualization tool. It's a part of an end-to-end data pipeline. Now comes the trend number 3, real-time decision making. Companies want insights as they happen, not after a month and a report. Power BI supports real-time streaming data. Power BI can ingest live event streams like IoT signal, transactions, or sensor logs and update visuals within seconds. This enables operational teams to monitor activity as it happens and respond almost instantly. Next, we have direct lake connectivity. Power BI reads data directly from Fabric's One Lake in its native format, and it can bypass imports and refresh cycles. It delivers near direct query freshness with import level performance for large scale analytics. Next is auto refresh dashboards. Power BI supports scheduled and automatic refreshes, ensuring dashboards always display the latest available data. This eliminates manual updates and maintains data consistency across teams and stakeholders. For example, a logistics company can monitor vehicle movement on live. A retail chain can adjust pricing based on real-time sales. A marketing team can track live performance of campaigns. Final thoughts? Power BI's importance in 2026 is not due to its charts. It's due to its speed and intelligence of insights. A business that operates with fast, consistent data insights outperforms competitors significantly. This is similar to how high-performance learners constantly analyze feedback and optimize their approach. Businesses that behave similarly using Power BI achieve superior outcomes. Now comes the section 4 of Module 1, Real-World Business Applications. Understanding theory is great, but what matters is real-world application. Let's look into how Power BI is used across industries, and I'll break it down by functional domains. The first one, marketing and sales analytics. Marketing teams rely heavily on Power BI for the following reasons. First one, lead generation funnel analysis, campaign return on investments, customer segmentation, revenue attribution, website and social media performance. Imagine you're running a YouTube ads campaign. Instead of manually downloading performance data, Power BI connects directly to YouTube Analytics or Google Analytics and creates a real-time dashboard showing the following visuals. So you will have a direct access to views, watch time, CTR, conversions, revenue. This allows marketing teams to optimize budgets immediately instead of losing money due to delays. The second one, finance. Finance departments use Power BI for P&L statements, expense forecasting, cash flow modeling, financial consolidation, aging analysis. The benefit is consistency. Instead of multiple Excel sheets floating around the organization, Power BI integrates everything into a single version of truth. Think of it like having an automated auditor that keeps all your numbers synchronized. Third one is HR analytics. HR uses Power BI for workforce planning, attrition dashboards, skill mapping, recruitment pipelines, diversity metrics. This helps HR leaders identify trends like which teams experience higher attrition or which skill gap can affect future growth. Now, the fourth one, operations and supply chain. For operations, Power BI acts as an operational command center. Companies track inventory analysis, manufacturing defects, supplier performance, order fulfillment times. This offers visibility from end to end, reducing bottlenecks and improving process efficiency. Now the fifth one, retail and e-commerce. In retail, Power BI is used to analyze daily sales, regional performance, product profitability, customer loyalty patterns, promotions impact, and Power BI helps these companies strategize inventory pricing and promotions. Conclusion: for this section, real-world value is what defines Power BI's credibility. Just like a learner becomes credible by consistently applying knowledge, Power BI becomes a credibility engine for organizations by delivering accurate, reliable, and timely insights. Now, the section 5 of Module 1, installing and setting up Power BI Desktop. Now let's walk through how to install and set up Power BI Desktop. Even though the process is simply straightforward, I want to explain each step, and it matters because understanding the environment makes learning advanced concepts easier later. Step 1, which is about downloading Power BI Desktop. Navigate to powerbi.microsoft.com, like the link I've shown on the web page. Go to the download section and you can download it. The second option, however, is the Microsoft Store itself. You can go to the Microsoft Store, go to the search bar, type Power BI, and then you'll get the app. You can download it from there and install in your local system. Both the steps are valid. The Microsoft Store version updates automatically, which is convenient for beginners. But if you are the person who is looking forward to continuing with the same version for a longer duration, then the first step would be better. Now, going into this step, second, installation. Choose the 64-bit version unless your system specifically requires otherwise. Once installed, launch Power BI Desktop and wait for the interface to load. Now comes the step number 3, understanding the interface. Power BI Desktop is divided into 3 major views. First view, report view. This is where you design dashboards. Second one is the data view. This is where you inspect raw data tables. And the last one is the model view, where you build relationships, define your data model. Each view plays a critical role. In the later modules, you will notice how frequently you shift between these views as you build complex solutions. Now comes the step 4, connecting to the data sources. Power BI supports over 160 plus data connectors, including Excel, CSV, SQL Server, SharePoint APIs, web data, cloud storage, Dataverse. Even IoT data can be streamed directly into Power BI. During the installation training, we typically load from a simple Excel file like financial sample or employee data or sales data to understand how columns and data types can be detected by Power BI. Now we go into step 5. The step 5 will be about configuring settings. Key configurations include regional settings, which is important for date formats, auto recovery settings, which is important for preview features like on object interaction. Next step is about enabling Copilot if available for your tenant. These small details significantly influence your user experience. Now the conclusion. By the end of installation and setup, learners should be comfortable navigating Power BI Desktop. This foundation is essential because starting from the next module, we will dive deep into importing, Power Query, transformations, and data modeling. Now that was the end of Module 1. Now we will dive into Module 2, which is about understanding the Power BI workflow. Welcome to Module 2 of our Power BI Fill course. In Module 1, we got a complete understanding of Power BI as a tool, why it matters in 2026, and how organizations across industries depend on it. Today, now, we're going to dive deeper. This module is all about understanding the Power BI workflow, the exact step-by-step process that transforms raw, unstructured business data into meaningful dashboard that executives rely on decision making. Think of this workflow as the operating system behind the Power BI. Just as successful learners follow a structured learning path to reach mastery, successful analysts follow a structured BI workflow to create credible, reliable business insights. Now, the section 1 of Module 2, Understanding the Power BI Workflow. Now, the part 1. What is Power BI Workflow? Let's start by the core idea. A Power BI workflow is the complete life cycle of your data inside the Power BI ecosystem from the moment you import the data. Here's a sharper, insight-driven version of your end-to-end analytics workflow structure, like a value chain rather than a simple sequence. This keeps it analytical, avoids marketing fluff, and clearly highlights how each stage contributes to business decisions, from raw data to decisions. The complete analytics lifecycle data import, you start by pulling information from multiple sources like CRM exports, SQL databases, API, or cloud storage, ensuring the dataset represents the business data reality accurately. Next is the data cleaning. Next comes the eliminating noise step, fixing missing values, correcting inconsistencies, normalizing formats, and validating data quality. Clean data increases reliability and reduces downstream errors. Data modeling is the next step. You then define the relationships, apply business logic, and structure the dataset into meaningful views or star schemas. This step shapes how metrics like revenue, retention, or conversion rate will behave. Visualization and insight generation is the next one. With a structured model, you build dashboards, KPIs, and trend analysis that highlight patterns, anomalies, and performance drivers. This is how you transform raw metrics into intelligence. Next, we have report deployment. Reports are then published into platforms like Power BI Service, Tableau Server, or cloud dashboards, ensuring role-based access, refresh schedules, and governance. Followed by that, we have decision enablement. Ultimately, these insights support strategic actions, optimizing campaigns, improving customer journeys, allocating budgets, and forecasting outcomes with data-driven clarity. Everything fits into workflow. This workflow is important because it ensures consistency, just like manufacturing industries follow a standard operation process. Data analytics team follow the Power BI workflow to maintain accuracy and speed across the reports. Now, the part 2. Why understanding the workflow is critical. Most beginners jump into visuals immediately. They drag a field, create a chart, and think that Power BI is just about visuals. But in real business scenarios, visuals represent only 20% of the work. The remaining 80% comes from data preparation. This is where raw inputs become analysis ready. It includes profiling data, handling missing values, correcting inconsistencies, standardizing formats, and shaping the data into usable structures. Good preparation reduces noise and ensures that upstream modeling remains stable. Modeling. The key goal here is to translate business logic into logical data structure. Fact and dimension tables are organized using schemas, hierarchies, calculated tables, and metric definitions mirror how the business measures revenue, performance, or customer behavior. A strong model determines the accuracy of every insight downstream. Followed by that, we have DAX. DAX is the analytical engine behind meaningful metrics. It enables time intelligence, filter, context manipulation, rolling calculations, and KPIs that behave dynamically. When models reflect structure, DAX inject intelligence, turning static data into performance-driven measures. Engineering proper relations is the next step. Correct relationship ensures context flows accurately across the tables. Cardinality, direction, and granularity must align with the business process. Proper relationship engineering prevents ambiguity, avoids circular dependencies, and ensures metrics aggregate exactly as intended. Understanding the workflow helps you avoid broken dashboards, A clear workflow ensures every step, data ingestion, transformation, modeling, and visualization follows a predictable structure. This minimizes mismatched fields, broken visuals, and errors that surface when datasets change. Next is all about understanding how filter contexts go through your model prevents inflated or deflated numbers. Proper modeling plus DAX discipline ensures totals, subtotals, and KPIs reflect real business logic instead of accidental aggregations. Next, we have an important step which is about fixing performance issues. A structured workflow highlights where bottlenecks originate, heavy queries, poor relationships, unnecessary calculated columns, or non-optimized DAGs. It helps you diagnose and fix slow dashboards where they impact the users. Build scalable reports is our next step. When the workflow is consistent, your reports scale gracefully with new data sources, additional KPIs, or even larger datasets. A clean pipeline reduces redesign effort when businesses need to grow. Reduce refresh failures is our next step. Clear preparation and proper modeling reduce schema, mismatches, query timeouts, and dependency problems. Your data pipelines remain stable even as refresh volumes increase. Next, after that, we have create data that business teams can trust. A disciplined workflow results in consistent, predictable metrics. Team sees the same numbers everywhere, which strengthens confidence, supports decision making, and ensures your dashboard becomes the single source of truth. Basically, it helps you protect data credibility, which is the foundation of analytics. Now we enter the part 3 of module number 2, the 5 pillars of Power BI workflow. The first one, data collection. This is the starting point. Power BI connects to more than 120 plus data sources, including Excel, SQL, SharePoint, Web APIs, SAP, Oracle, Snowflake, and so on. Data usually comes in different formats. Flat files like .csv, operational databases, analytical warehouses, cloud platforms, streaming data sources, and a lot more. In real-world companies, data is scattered. One team keeps Excel files, another has SQL databases, marketing uses a CRM, sales uses a different system. Power BI becomes a centralized platform where all these data sources converge. Now, the second one, data transformation, Power Query. This stage is one of the most important one. Think of Power Query as the data cleaning refinery. Just like crude oil cannot be used directly, it needs to be refined. Raw business data needs cleaning before it is usable. Power Query handles many important stages like removing duplicates, fixing headers, splitting and merging columns, converting formats, handling null values, replacing errors, joining tables, cleaning inconsistency, category naming, creating calculated columns, and a lot more. This stage ensures the data is trustworthy, and without trust, no dashboard is valuable. Now comes the third pillar, data modeling. This stage is where Power BI becomes the most powerful. More than Excel, data modeling is the process of structuring your data for analysis. This is the blueprint that decides how Power BI calculates numbers. Key elements include fact tables. These hold numerical, event-based data such as sales, transactions, or clicks. They represent what happened in the business and typically contain high volumes of rows. Facts drive aggregation and they are the backbone of KPI calculations. Dimension tables are the next ones. Dimension tables describe the business context like customers, products, dates, regions, or employees. They enrich fact tables with attributes that help slice, filter, and segment the insights. Dimensions make reports interactive and meaningful. Star schema. A star schema places a central fact table at its core connected to multiple dimension tables. This structure improves performance, simplifies DAGs, and ensures clean filter propagation. It is the recommended modeling standard in Power BI. Relationships. Relationships define how tables connect and how filters move between them. They determine the analytical behavior of visuals and calculations. Strong, properly configured relationships eliminate ambiguity and guarantee accurate results. Cardinality. Cardinality is described as the type of relationship. There are many types of relationships: one to one to many, many to many, and many to one are the basic examples. The correct cardinality ensures that data aggregates properly and prevents unexpected duplication or mismatches when calculating KPIs. Cardinality. Cardinality describes the type of relation. So the types of relation can be of different ones: one to many to one to one, and many to many. The correct cardinality ensures the data aggregates properly and prevents unexpected duplication and mismatches when calculating KPIs. Now let's go through cross-filter directions. Cross-filter directions determine how filters flow single direction, which is the most common one, or the bidirectional one. Single direction keeps the model stable, while bidirectional is used carefully for specific scenarios like many-to-many relationships. Now let's go through DAX measures. Measures convert raw data into meaningful business metrics such as revenue, retention, or year-on-year growth. DAX leverages filter content, time intelligence, and aggregates to produce accurate dynamic calculations across reports. A strong model ensures reports run faster, numbers aggregate correctly, filters work properly. You can slice and drill down insights. Companies heavily invest in modeling because it reduces conflicts such as wrong totals, duplicate counts, slow performance, and confusing visuals. Now, let's deal with visualization and storytelling. Most people think dashboards are equal to visuals, but visuals without a narrative are incomplete. Visualizations include the following: building charts, choosing the right visual type, using slicers, adding filters, highlighting KPIs, and structuring pages. Good dashboards answer business questions such as what happened. This focuses on descriptive analytics. Dashboards summarize historical performance, sales, traffic, conversions, production output, or customer activity. The goal is to provide a clear, immediate snapshot of business performance without any ambiguity. Now, the next one is, why did it happen? This moves into diagnostic analytics. Power BI allows teams to drill down, segment data, compare cohorts, and analyze patterns that explain the drivers behind the results. It helps identify root causes, pricing changes, seasonal shifts, operational issues, or marketing impacts. Now, followed by this, we have what will happen next. This represents predictive analytics with features like forecasting, machine learning models, to fabric and trend analysis. Power BI helps anticipate future behavior, expected sales, customer churn, demand spikes, or risk exposure. What action should we take is the next question. This question supports the prescriptive analytics. Dashboards guide decision making by highlighting opportunities, risks, and required adjustments. Whether it is reallocating budgets, optimizing workflows, targeting profitable segments, or improving supply chain operations, insights translate directly into actions. Your goal as an analyst is to convert the data to insight and insight to action. Now comes the fifth point: publishing and sharing governance. Once the report is ready, it must be delivered to the right audience. So the right audience could be managers, sales leaders, finance heads, marketing teams, or operation teams. Power BI service enables cloud-based sharing, row-level security, data refresh scheduling, collaboration with teams, integrations with teams, Excel, SharePoint, etc. This final stage ensures business users get reliable, updated dashboards without manual effort. Now let's go to the section 2, which is about overview of Power BI desktop, service, and mobile. So the part 1 in this is about Power BI desktop. So Power BI desktop is where 90% of the analytical work happens. This is your development environment, the workshop for building analytics. Now let's go with the key functions. The key functions are data import. This is the entry point of the Power BI workflow. You pull data from files, databases, cloud systems, APIs, or enterprise warehouses. The objective is to bring raw data into the environment efficiently while preserving the structure, precision, and metadata. Next is data transformation. Using Power Query, the raw inputs are cleaned, structured, and standardized. This stage fixes errors, handles missing values, merges tables, applies business rules, and reshapes datasets. Clean transformations reduce downstream complexity and ensure consistent analytics. Now, let's go with model design. Here, data is structured into logical schema, typically fact and dimension tables. Proper relationships, cardinality, IRR, and data granularity are engineered to support accurate slicing, filtering, and aggregation. A strong model is the backbone of reliable dashboards. Now, let's go with DAX calculations. DAX converts the model into intelligence. Measures define KPIs like revenue growth, conversion rates, year-on-year performance, and operational efficiency. Good DAX respects filter context, enables time intelligence, and enforces business logics across visuals. Report creation visuals are built to communicate insights clearly. Charts, maps, tables, KPIs, slicers, and storytelling elements. Reports aim to answer business questions, highlight performance trends, reveal drivers, and support decision making through clean, intuitive design. It has a very structured interface. Now, let's go with that. The first one is the report view. This is the canvas where the insights come to life. You build visuals, arrange layouts, apply themes, and craft the storytelling layer of your dashboard. It's designed for rapid experimentation, letting you iterate on charts, KPIs, and interactions that answer business questions. Now, the second one, the data view. This view lets you inspect the transform table outputs row by row. It's used to validate common values, check data types, and verify the results of Power Query transformations. Analysts rely on it to ensure data quality before modeling and DAX creation. The last one is the model view. Here, you design the logical structure of your dataset. Tables, relationships, cardinality, filter directions are managed visually. The model view ensures your schema reflects real business processes and that metrics aggregate predictably across dimensions. The model view ensures your schema reflects real business processes and that metrics aggregate predictably across all the dimensions. Now let's discuss about the visualization pane. This pane provides full library of charts, maps, KPIs, matrices, and custom visuals. Each visual has configurable properties, formatting, interactions, data roles, conditional formatting that help turn raw data numbers into strong analytical narratives. Now, let's go into the filters pane. This pane controls all filters applied at visual, page, or report level. Proper filter usage ensures users see the right slice of data and that calculations reflect accurate context. It also helps fine-tune interactivity, comparisons, and scenario exploration. Now, let's go with the data fields pane. This lists all tables, columns, and measures in your model. It's the core workspace for dragging fields into visuals, building new measures, controlling hierarchies, and managing calculated fields. A well-organized fields pane accelerates reporting efficiency. Analysts spend most of their time here because this is where insights are engineered. Power BI Desktop is free. This makes it accessible to students, beginners, and companies of all sizes. Now comes the part 2, Power BI Service. Power BI Service is the cloud platform. Once reports are ready, they are published here. Its key features include creating dashboards, managing workspaces, scheduling data refresh, viewing reports online, organizing analytical assets using the Power BI app, embedding reports into websites, row-level security, and collaboration in Workspace. In 2026, Power BI Service is deeply integrated with Microsoft Fabric and Microsoft Copilot. Microsoft Fabric brings data engineering, data science, real-time analytics, warehouse workloads, and lakehouse architecture, all inside the same environment. This makes Power BI a front end for entire modern data stack. Now let's go through the part 3, Power BI Mobile. The third component is the Power BI Mobile. This is crucial for decision makers who are always on the go. Executives want quick snapshots, alerts, sales performance, market trends, and operational bottlenecks on the go. Power BI Mobile allows them to monitor business performance in real time. Many companies rely on mobile dashboards during morning sales stand-ups, weekly reviews, executive board meetings, and many more. Together, the desktop, service, and mobile form a complete ecosystem. Now, let's dive into the section 3. Typical workflow explained with some examples. So let's consider an example. Retail chain with 50 stores. Let's look at a practical example. You're a business analyst for a retail company that has 50 stores across the country. Now the management wants a dashboard showing daily sales, category-wise performance, store revenue, and top-selling products. Now let's walk step by step through how you build it. Step 1. Connect to data. You connect to Excel for daily sales, SQL Server for inventory, CSV export from POS. Power BI combines all these three data sources seamlessly. Step 2. Clean the data. In Power Query, you fix the category mismatches, remove duplicates, correct date formats, merge store metadata, handle missing values. You ensure that the data satisfies real-world business logic. Now comes the step 3. Build the data model. You create a star schema, fact sales, dimension product, dimension stock, dimension date. You establish relationships. Then you write DAX measures like total sales, profit margin, average basket, size, year-on-year growth. Now, the model can answer the business questions almost instantly. Now comes the step 4. Build the report. Your dashboard includes a line chart for monthly sales, a bar chart showing category contribution, a geographical map showing store performance, KPIs highlighting revenue tables, listing top products, filter for store, category, and date. Users can now drill down from total sales to city to store to product. Now, let's dive into the step number 5. Publish the report. Power BI service is your option. You can publish the report, then you set frequency, define permissions, create dashboards, distribute to leadership teams. Now, the entire organization uses your dashboard. Now, with that, let's dive into the section 4. Key components of Power BI interface. The first one, ribbon. This includes home, insert, modeling, view, and help tabs. Each controls a different part of the workflow. The second one is the views pane. This includes report view, data view, and model view. Each view offers different angle of analysis. The third one is the fields pane. This shows tables and fields. A well-structured field pane improves efficiency. The fourth one is the visualization pane. This is where you select charts, customize visuals, change colors, enable analytics lines, and format your visuals. Now the fifth one is the filters pane. Filters allow control over what data appears on the report page or a visual. Then comes the sixth one, which is canvas area. This is where visuals come together and form a meaningful story. And with that, we have finished the module 2, and now we make a transition to the module 3, which is based on connecting to data sources. Next comes the filters pane. This pane controls all filters applied at visual, page, or report level. Proper filter usage ensures users see the right slice of data and that calculations reflect accurate context. It also helps fine-tune interactivity, comparisons, and scenario exploration. The data fields pane is the next one. This pane lists all the tables, columns, and measures in your model. It's the core workspace for dragging fields into visuals, building new measures, controlling hierarchies, and managing calculated fields. A well-organized fields pane accelerates report efficiency, and analysts spend most of their time here because this is where insights are engineered. Power BI Desktop is free. This makes it accessible to students, beginners, and companies of all sizes. Now comes the part 2. Power BI Service. Power BI Service is the cloud platform. Once reports are ready, they are pulled and published here. Its key features include creating dashboards, managing workspaces, scheduling data refresh, viewing reports online, organizing analytical assets using the Power BI app, embedded reports into websites, row-level security, collaboration in workspace. In 2026, databases, cloud services, real-time streaming systems, APIs, big data engines, enterprise solutions, Microsoft Fabric and Azure resources, and a lot more. Data connectivity is the backbone of every Power BI solution. And in this module, you'll understand not only how to import data, but also why certain methods are chosen in real-world business environments. Now, the section number 2 is about importing data from Excel. Let's begin with the most common and beginner-friendly data source, which is Excel. Excel is still one of the most used analytics tool in the world, making the perfect start point. How to import Excel data? You can open the Power BI dashboard, go to Home, Get Data. So browse and select your file. Power BI displays the Navigator window showing available sheets and tables. Don't worry, this is just a quick theoretical approach. Once this is done, we will be directly diving into the demonstration mode where we will practically explore all these. Now, once you see the available sheets and tables, select the required items and click Load or Transform Data based on your request. Repeat. and click on load or transform based on your requirement. Then comes the important concepts. If your Excel file uses names, tables, Power BI treats them as clean structured objects. If your Excel file uses plain ranges or messy layouts, Power BI still imports them, but you will need Power Query to clean them later. Now, business relevance. Excel is widely used for monthly sales reports, budget, financial transactions, campaign tracking, ad hoc department level reports. This means data analysts frequently integrate Excel with larger systems like SQL Server, CRM data, and a lot more. Now let's also discuss some common issues and best practices. Ensure the first row contains column names. Avoid merged cells. Our query struggles with them. Keep date formats consistent. Try to use tables instead of raw ranges. Now let's go through an analogy. Think of Excel data as manually entered or department. Now let's go through an analogy. Think of Excel data as manually entered or department level data, like a student's personal note. They help with context, but they often require polishing before being shared. Now let's go through the section 3, which is about importing CSV data. CSV files are often another common data source, especially for exports from applications, websites, or tools. Now, how to import CSV? The same. Go to Home, Get Data, then you choose Text or CSV option. Select your CSV file. Power BI automatically detects column delimiters and data types. It also shows you a preview. Click on Load or Transform Data based on your requirement. Why CSV is important? CSV is a universal format used across marketing platforms like Facebook ads, Google ads, e-commerce reports, CRM systems, ERP exports, social media analytics, automation tools, payment gateway logs. CSV files are lightweight, system friendly, and easy to automate. Now, let's go through some key differences between Excel and CSV. CSV does not support formulas, no formatting, no multiple sheets, faster for automation and ETL pipelines. So basically, every CSV cannot be Excel, but Excel can be turned into a CSV. Now, let's go through some best practices. Treat CSV files as raw system output. They usually require data cleaning, but ensure more consistency because they don't contain any formatting errors. Now let's dive into section 4, which is about connecting to web sources. So next we explore one of the most powerful features, which is web data sources. Power BI can connect directly to websites or APIs and fetch structured data. Go to the Get Data option, enter the URL by choosing the web option. Power BI loads the HTML or JSON content. Select the required table or hierarchy, transform it and load it. For example, extracting stock market data or pulling cryptocurrency prices or getting live COVID-19 data, weather statistics, reading product listings, import government datasets, and a lot more. You can also go with API-based data like YouTube Analytics or Google Maps data and a lot more. Now let's also discuss a small use case. Imagine a company that wants daily currency conversion rates. Instead of manual downloads, Power BI can fetch real-time rates through a web API and keep dashboards always current. Now a small keynote, when using APIs, authentication may be required. API keys, tokens, OAuth, etc. Now let's also go through an analogy. Web data is like tapping into a live knowledge source. Similar to how learners use online platforms to stay updated instead of static files. You get dynamic, evolving information. Now let's go through the section 5, which is about connecting to databases. This section covers the enterprise grade side of Power BI, which is about connecting to databases. In professional environments, the most critical data lives in SQL servers, Azure, SQL, MySQL, Postgres Server, Oracle, Snowflake, Databricks, Azure Synapse, data warehouses, or lakehouses. Basically, anything which is a database online or on a data server. Power BI connects seamlessly to all of them. SQL Server connectivity steps are as follows. Same, you need to go to Home, select the Get Data option, and select SQL Server or any of the database where your data is existing. Enter the server name, database name, which is completely optional. Choose the Import Query option, Dual Mode, provide credentials, select the tables that you need on your Power BI window, and then, based on your requirement, either transform the data or load. SQL Server is extremely common for storing sales transactions, customer data payment, information, inventory, employees, employee data, ERP data, CRM data, and a lot more. Why it matters is the next question. Database connections allow you to integrate large, structured, professionally maintained datasets. This gives your report enterprise credibility, similar to how a researcher gains credibility by referencing authoritative resources. Now, Azure Cloud Database Connections, Azure SQL Database, fully cloud-hosted SQL database used by modern businesses for scalability and low maintenance. Azure Synapse Analytics. So Azure Synapse Analytics is an enterprise warehouse for big data and analytics. Azure Databricks for AI and ML and large-scale data processing. Azure Data Lake for massive unstructured and semi-structured data storage, business-relevant insight, cloud database support, real-time dashboards, large data volumes, global reporting, multi-department analytics, and a lot more. Companies adopting cloud architectures rely heavily on Power BI to interpret their cloud data ecosystem. Now we enter the section 6. Data load versus data import versus data query. This is one of the most important concepts in Power BI. How to load your data determines the performance of your report, the freshness of your insights, size of your dataset, the speed of processing. So now let's break down the 3 modes the Power BI offers. The first one, import mode, and how it works. Data is copied from the source into Power BI's internal storage, and it is through Vertipack engine. Fast performance, best for dashboards that don't require second-by-second updates. Now, where is this ideal? It is ideal for small to medium datasets, analytics dashboards, visualizations, monthly or weekly reporting, and it deals with Excel plus CSV plus SQL tables. Now, let's also discuss the benefits. It is extremely fast in queries, full Power BI functionality, compression can be done up to 10 to 20 times, and there are also some limitations. Let's go through them. Data size is limited, not suitable for real-time systems, and let's also discuss some of the real-time examples. So one of them is monthly sales report where data refreshes every morning. Now the second type is direct query mode. Now let's discuss how it works. Data stays in a database, Power BI queries the source in real time. No data is stored in the Power BI itself. It is in the database. Now, where it is ideal? It is ideal for real-time dashboards, very large databases, enterprise-level systems like SAP, Oracle, or Synapse. Now, let's also discuss the benefits. Always fresh data, no dataset size limitations, and apart from these, we have some disadvantages. Let's go through them. It is slower in performance. Many DAX features are unavailable. Load depends entirely on the database, and visuals refresh very slower. Let's also discuss one of the real-world examples. A logistic company monitoring real-time vehicle movement is a perfect example for this one. Now comes the third one, which is about the live connection. It is mainly used with analysis services, Azure Analysis Services, Power BI dashboards, Microsoft Fabric semantic models, and a lot more. It behaves similar to direct query but optimized for enterprise models. Now, what's the key decision rule here? Choose import mode unless you need real-time insights, your dataset is too large to import, your company mandates live connection for governance. This decision is strategic choice similar to selecting the right learning strategy. This decision is strategic choice similar to selecting the right learning strategy, which is like memorizing versus understanding versus applying. Each has strengths and constraints, and choosing the right method enhances efficiency. And with that, we have come to the end of Module 3 and we transition into the Module 4. So the Module 4, which is all about data transformation with Power Query Editor. So welcome to Module 4 of our Power BI course. In this module, we will explore Power BI's Power Query Editor and one of the most essential tools in Power BI for preparing and transforming data. Think of Power Query as the foundation of your analytics workflow. Without a strong foundation, even the best dashboards can give misleading insights. Cleaning and transforming data ensures that reports are accurate, reliable, and actionable. In this real world, most datasets are messy. They contain nulls, errors, duplicate rows, inconsistent formats, or unnecessary columns. Power Query gives you the tools to handle all of these in one go. Power Query helps you with repeatable automated way where you can once define these steps and Power Query will take care of them in the flow. Now, the section 1, Introduction to Power Query Interface. When you open Power Query, you will see a structured workspace designed to make transformation easy and intuitive. At the top, we have the ribbon. It contains tabs like Home, Transform, Add Column, and View. Each tab provides key commands for shaping your data. And on the left, you see the queries pane, which lists all the tables and queries in your project. You can select rename or reference queries from here. The center of the screen shows the data preview grid, where you can see your data table and apply transformations. On the right side is the applied steps pane, where every change you make to your data is recorded as a step. And this step-by-step process is extremely powerful. It allows you to track, edit, or remove any transformation without starting over. Finally, at the top, there's a formula bar where the displays Finally, at the top, there is a formula bar which displays the underlying M code for each transformation. Even if you never write the M code manually, understanding that it exists helps you appreciate how Power Query automates and records your steps. Now comes the section 2, cleaning the data, removing nulls and handling errors. Data cleaning is often the most time-consuming part of any analytics project, but it is also most critical. Let's start by null values. Null values appear when the information is missing in a dataset. For example, a customer record might not have an email address, or a sales transaction may be a missing discount, or a lot more. In Power Query, you can choose to remove these null values. Replacing nulls is usually better than removing them completely, especially when the missing value has a business meaning. For example, a null discount might simply mean the product was sold for a full price. You can replace nulls with zero, average values, or even label them as unknown depending on the context. Next, we have handling errors. Errors occur when data is incorrectly formatted, calculations fail, or conversions don't work as expected. Power Query lets you remove errors, replace them, or investigate them. For instance, if 50 rows of date values fail to convert, you can check why. Perhaps the format was inconsistent or the data was entered incorrectly. Lastly, let's talk about the duplicates. Duplicates can inflate metrics and distort insights. Power Query allows you to remove duplicates either across entire rows or selected columns. But be careful. Sometimes repeated entries are legitimate, such as multiple orders from the same name or the same customer. Always analyze before removing any duplicates. Now, with that, we enter the section number 3, which is about the column transformations. Once your data is clean, the next step is about transforming columns to prepare them for analysis. Changing data types, every column has a data type, such as text, number, date, or boolean. The correct data type is critical because calculations and visuals rely on them. For example, if your sales column is text instead of a number, sums and average will fail. Splitting columns. Splitting columns is useful when a single column contains multiple pieces of information. For example, a full name. A full name column can be split into first name and last name. Similarly, a product code like PRD123USA, which can be split into category, ID, and country. Extracting values from Power BI allows you to extract specific parts of the column. First characters, last characters, ranges, or patterns. You can also extract years from dates, domains from emails, or UTM parameters from marketing URLs, conditional columns, or UTM parameters from marketing URLs. Next is conditional columns. Conditional columns let you create logic directly in Power BI query. For example, if revenue is greater than 50,000, mark the row as high value customer. This ensures that business logic is applied before the data reaches your visuals. Next is group by. Grouping helps you summarize granular data. You can calculate total sales by region, average orders value by product, or counts by the customer. This is particularly useful when preparing large datasets or dashboards. Now we enter the section 4, merging queries. Merging queries in Power BI is equivalent of SQL joins. You can combine multiple tables to enrich your dataset. For example, you might have a sales table and a customer table. By merging them on customer ID, you can add customer names, regions, and other attributes to the sales table. Types of joins include left join, right join, inner join, full outer join, and anti-joins. Merging is essential in real-world analytics because data often resides in different systems. By merging correctly, you can create a unified dataset that drives reliable insights. Now we enter section number 5, pivot columns. Pivoting converts row values into column headers. For example, if you have monthly sales in rows, pivoting months turns them into separate columns for easy comparison. Pivoting is often used when creating matrix-style dashboards. unpivot columns. Unpivoting does the opposite. It converts columns into rows. This is particularly useful when you receive wide format data such as budgets or survey results because Power BI works best with long format tables. Now let's move into advanced splitting. Beyond simple splits, you can handle complex cases. Splitting product codes into multiple dimensions, extracting UTM parameters from URLs for marketing analysis, separating full names or addressing into components. Mastering pivot, unpivot, and splitting gives you full control over how data is structured, ensuring that your models are both clean and analysis ready. Now, the conclusion to the module 4. To summarize module 4, Power Query Editor is the backbone of Power BI. It allows you to clean, transform, and reshape the data in a repeatable and efficient way. By mastering these skills, cleaning nulls and errors, transforming columns, merging queries, and pivoting and unpivoting data, you ensure that the data feeding your reports is accurate, reliable, and structured for analysis. In the next section of this module, we will dive deeper into demonstration of data connections on Power Query, where we will use these clean and transformed datasets to build relationships, create measures, and enable advanced analytics. So now we are in the part B of Power Query. So part B of Power Query is all about importing data from multiple variety of sources. So your data can be in a cloud storage, in a database, in an Excel file, in some folders, in PDF, in WebPreet, which can be analyzed is your data for your Power BI. That's the source for you. So Power Query helps you with that. It can extract the data from any source you get to it, and it will make the data ready for exploration, insights, and analytics. Now we will be exploring that particular tool in our session for today. So let's go with the dataset that we are dealing with today. So in this particular demonstration, we will be using Excel files, folders, and we'll also using web scraping for our dataset. And these are the wide variety of datasets that we will be dealing with today. And we'll also be performing some merging and joining operations as well. So let's get started with the simple dataset for now, for learning purposes. So this is our employee dataset. So we have the first column, which is name column. The second column is the gender column, the department column, salary location, and the start date as well. So in the first column, we have unique names, and in the second column, we have gender. So this particular dataset has some elements missing, right? You can see in the gender column, we have some blank cells as well. And in the department column, we have a lot of options: business development, training, engineering, research and development, product management, support, human resources, etc. But along with that, we also have few departments named as nulls, right? So remember this. In a few situations, you might recruit an employee, right? Here you can see this particular employee was recruited in the year of 2025. So maybe he's on bench period. So maybe he's an intern, or maybe the company just hired him based on his, or the company's requirement. He might be moved into a dedicated team. So there was a little misunderstanding or something going on in process to dedicatedly appoint that employee to a specific domain, right? And apart from that, if you see the salary section, you also tend to see some blank columns or blank rows or blank cells, right? So no blank columns, it's blank rows actually. So you can see another blank here. So these are a few inconsistencies that we have in our data set. And apart from that, if you see the location details, in the first row, you can see 3 Redmond Bay Bellevue and Washington, USA, right? So the problem is, let's say you wanted to extract the country, but you might feel we have this particular data in a comma separated format, so you can quickly go to data validation and separate the columns based on delimiter. But is it the same? No. If you expand this particular cell, you can see this particular data is entered in a new line, but not comma separated. So that's the problem, right? And how would you apply split or delimiter based data validation here? That's difficult. But Power Query has a good tool for yourself. So the thing is, you can explain Power BI what your intention is. Like, let's say you just extracted the first or last few words of your particular location. Let's say, since this is USA, I want to extract the last 3 letters in this particular location. You can extract it. But down the line, if you have different countries, maybe Australia, then what it does is it will separate only the last 3 letters of Australia and the rest will be left out. So this is not the way you want to work with your data set, right? So for this, you might have to work in detail with your formula. You might have to struggle writing the formulas for that, but don't worry. If you're not so strong with the formulas and if you're facing tough time to recognize the text character based functions, you can just write few cells. It's like flash fill in Excel. You can explain your intent to your Power Query tool and it will understand what you're trying to extract, and based on that it will extract the data for you. As simple as that. We will be also working on that. And lastly, we have the start date column. So this is the rough overview of our dataset. Now let's go to Power Query. So for that, you might have to go to a new blank workbook. So we can continue with Excel here, but you can also continue with Power BI as well. Why Excel? Because the Power Query interface will be completely same compared to Excel as well as Power BI. So both are Microsoft products. So on Power BI as well as Excel, you will have the same interface for Power Query. So for learning purposes, let's also explore Power BI as well. Now let's create a blank report. And here you can see the get data option, same like Excel. So if you go to data, here you have the get data option, and you have a wide variety of sources. You can choose from Excel, you can choose from text or CSV, you can choose from XML, you can choose from JSON, you can choose from .pdf, or you can also provide a folder. So we'll also deal with the folder option. So in the future use case, we will be creating a sales dashboard where we will be having year-on-year data set. So we'll be having a data set from 2020, 2021, 2, 3, 4, 5, and 6. So you will have a wide variety of sales files, and that particular folder will be saving all these files. Let's say tomorrow you'll have 2026 data or 2027 data on future data sets. What you can do is just drag and drop the file in that particular folder, and Power Query and Power BI Desktop will automatically understand new data has been added to the file, and it will run all the steps we have made Power BI or Power Query to learn and get the data ready for analytics. So we'll also be exploring that. And apart from files, you also have a database. So here you can get connected to SQL Server database, Microsoft Access database, analysis services, SQL Server analysis, and apart from that, you have Azure. So we also have Azure, as we discussed in the part 1 of this particular module, the 4th module. We also can connect to Azure as well as Azure Data Explorer. So you need to have some credentials for that, but don't worry. So for the basic understanding purposes, we'll be dealing with the website data, we'll be web scraping the data, we'll be loading data from files and Excel documents, etc. And you also get some other sources as well. You can, as we discussed, the web and ODBC, OL, EDB from picture. You can also post a single picture just like AI does today. You just post a picture, it will build websites for you, it will extract the data for you. So the same feature is also integrated into Microsoft Power Query as well. You can combine queries where you can append the data or merge the data. Similar to SQL join operations, you can also Power Query editor, you can launch it, and a few more query options. Let's say you wanted to edit a particular step. Okay, when we dive into the Power Query editor, you will see the steps on the right hand side and the queries on the left hand side. So based on that, if you wanted to edit a particular step, you can also do that. So this was the option from Excel. Apart from this, if you go back to your Power BI window, you can see a similar interface. You can go to get data and you can also go to more here, and you have you have file, a database, Microsoft Fabric. So remember Microsoft Fabric, it's the new integration into Microsoft Power BI for data. So it's like a data lake, and you have Power Platform, Azure Online Services, others, right? So I think you already know the detailed differentiation between a data warehouse and a data lake. So roughly, a data lake is where you don't have organized rows and columns. It's like you'll have a wide variety of resources. You have images, multimedia, and all of those, and you can choose this particular data lakes are very essential for machine learning purposes. You can choose what type of data you want to deal with and you can directly access it. You don't have to modify and forcefully store the data in dedicated columns and rows. So those are data lakes. You can also explore that further in the data lakes tutorial on our channel. So apart from this, these are the data sources. You can also connect to a SQL Server, Access database, and a lot more. So let's go back to the basics. So we are on the new Excel spreadsheet here. Now all we need to do is quickly import the data from the Excel file. So I'll go with the Excel dataset, and the first dataset that we will be exploring is Excel workbook. So I'll be selecting the Excel workbook here. Now we need to navigate. Let's give it a little time to open the browser window. So my data is in downloads. So Power Query examples, datasets, and here is the employee dataset that we were discussing previously. So click on import and it will take a little bit of time to load the data. It's establishing a connection. Now, any moment you can see a Power Query window. So there you go. So here you have just one file. So it's showing you the preview directly. In some situations where you have multiple files, just like we discussed before, sales data from 2020, 1, 2, 3, 4, 5, 6, and beyond. In those scenarios, you might just have one file available for you on the preview. But in case if you wanted to see all the files, you have a little option here, the checkbox, which says select multiple items. So if you just click on it, it will give you all the datasets available in that particular file. And now I just have one, so you can just click on that particular data and you have a quick preview. So when you click on the dataset here, when you uncheck this, you cannot see the load options, right? But if you click on this, you can unlock or activate the load, transform data, and cancel options. So what these does is, let's say you're completely happy with the data you have. We know that your particular dataset is completely clean and ready for analytics. What you can do is you can directly load the dataset onto your analytics platform. But now it is Power BI, right? You can directly load the data into Power BI and get started with your analytics like building charts, graphs, even dashboards, interactivity. You can add filters, slices, etc. But in case your data is completely raw and you need to manually filter it, then you need to go to the transform data option. So now, since we know that our data set needs some cleaning, we will click on the option that says transform the data. So click on transform data and soon you have a quick Power Query window. So as we discussed, the right hand side will be the steps, applied steps will be recorded. And on the left hand side, the queries that we are applying on our data set. So in case if you wanted to edit any query, you can quickly come to this section and choose to edit the options. And on the right hand side, you can see already Power Query window has took the liberty to make some changes to your dataset, right? So the first one is it chose the source, then it navigated the source, and it promoted the headers. So what has promoted the headers? If you go back to the dataset, here you can see the first row is name, gender, department, salary, location, and start date. So Power BI's Power Query or Excel's Power Query was intelligent enough to understand that the first row entry is the metadata or column header, or you can call it the name of the column in most layman's terms. So it understood that this is the row header, so I need to push this as the column header or the row header, and it took the liberty to do that. And apart from that, it also took the liberty to change the data type. So if you come back to the original data set, you can see it understood the format. So we have the dollar symbol, right? It automatically understood that this particular number should be a whole number because this is a salary number. And the location details are automatically set to character. You can see the ABC logo here, and you can see the 1.2 symbol, which means the whole number with decimal points. And you can also see the ABC character data type for department, gender, and name, right? So these are the few steps which Power BI took the liberty to help with us. And now let's go with the first requirement that we were talking about. In the original data set, we had some errors, right? So we had some null entries. So we need to change that. So here you have the option. But before we begin with any operations, let's have a quick overview on the ribbons we have. So here you have the close and load option. This is the most important one. Whenever you apply all the steps you need and you're happy with the dataset transformations, then you come here and choose the option to close and load. What this basically does is it saves all the transformations that you apply to your dataset and saves them, and then loads the data to your Power BI platform or any platform you choose. So you have two options here: load, like close and load directly, or if you choose a different one, let's say you wanted to load to the Power BI platform, you can choose that. So the default close and load will load this particular data to the Excel because we're working currently on Excel. So that's how it works. And next comes the refresh preview option. Now, what is refresh preview option? As we discussed, in a file, there could be chances that you might add new data eventually. So whenever new data is added eventually, you just need to click on the refresh preview and Power BI will automatically understand there is new entry for the data, and what it does is magical. It takes its navigation directly to the applied steps. So here it changed or applied a few steps here. So it again changes the data type, it changes the promoted header step. It will remove the first row and it will automatically think this is the column header and it will promote it to the column header. And apart from that, if we are going to perform some operations here, like adding others to the gender column and changing the null value to engineering or any dedicated department, and then in salary section, if you remove the null values and then if you separate the country from this particular location column, it will record all those steps and it will automatically implement these new steps, these particular steps onto the new data. And you don't have to do this repeatedly. The most important aspect of using Power Query is automation. So the entire part of your data transformation will be automated. And whenever you load new data, you don't have to, worry about anything. Power Query will handle all the transformations and gets your data ready for your next step, which is data visualization. That's the magical part of Power Query. And apart from that, you have properties, manage, and choose columns. If you go to choose columns, let's say I just want name and department here. Now what I can do is I can choose the columns and then it will give me a window. So let me go ahead with that. So it will give me a window where I have the liberty to choose whatever columns I want. Let's say I want to go with name and department. It will give me only name and department and any other things which we want to go ahead with. So that's the best one. And remove columns. So here you can see promoted to headers, right? But in case, if let's imagine that our dataset had some misconceptions, like the first column or the first row was completely empty. In those scenarios, Power Query will consider that empty row or an empty column as a null value. And we don't want that null value. In those scenarios, you can choose to remove that particular column or that particular row completely. And you can see a similar option here, keep rows and remove rows. And the similar options like Excel, where you can sort the data in increasing order or decreasing order. And remember the column splitting that we spoke about, the data validation option that we used to have in regular Excel, where it identifies the delimiter and splits the data into columns, right? So that option is here, and you can also go ahead with group by options and use first row as headers. So this was the step I was talking about. Power Query automatically did that for you. You don't have to worry about it. And replace values, we'll be using this replace values. So the first place where we have to use these is replace the null values with a dedicated value you want to add in. And apart from that, you have merge queries option, append queries option, and manage parameters, data settings, and a few others. And here you have the transformation option where you can transpose the data, reverse the rows, count the number of rows, use first row headers. You can fill some data sets, and you have pivot and unpivot columns option here. We'll also be exploring that. And you have extract the data, parse the data, statistics, standard deviation, and scientific columns. And you also have a date option here because we have date column here, right? And you can also choose to add some customized columns as well. Remember the column I told about where you don't have to worry about the formula. You just have to explain Power Query what is your intention and it will extract the data for you. That's the one here. So you can choose to have a custom column, or you can also choose this particular one. Our requirement is column from example. So you will add a new column. You will provide few examples from the location. You'll just write USA, and in the next one you'll write the next country, which is New Zealand, NZ, and so on. So based on your requirements, based on what you're applying, it will think like you. It will understand your thought process, and based on that, it will help you extract the countries. That's magical, right? So no worry, we'll also go through that in a moment. And the last one is conditional column, duplicate column, all those. And the last one is the view one here. So you have formula bar. Okay, remember the formula bar. For now, you have this particular formula bar. Let me highlight that, right? So I've done this a few times, so I have this particular column option available. So in few scenarios, if you're new to Power Query, in very rare scenarios, the formula bar is not visible. In such scenarios, what you can do is you can go back to the view option and enable the formula bar so that you can see this particular formula bar and see what is the operation being run on your particular data set. So this was a quick overview of your ribbons on Power Query window. Now let's go back to the home ribbon, and here the first operation, department. So we will be replacing the null values with some dedicated value that you are interested in adding, right? So yeah, I think we missed out the second column. This was the gender column. We need to work on this first. So you just need to select the column, and there are multiple ways to do this. You can, go to the add column or transform option and choose the replace values from here, or simply right click and then you have the option which says replace values, right? So for now, I think we have null, the empty value. So there are two meanings for it. If it is lowercase null, it means the columns or that particular cell is blank. But in case if it is capital null, then it means it is character data type and it was dedicatedly written as null, right? So you need to understand the basic difference between nulls. So this is the null value we're dealing with. And in place of any blank cell where the value is null, let's write it as others. So others will be the gender in place of a null value. And this will be your first transformation step. And take a look on the right hand side. So whenever I click OK, a new step will be registered. So that was the replaced value, and a new step has been successfully registered. So if we scroll down the data, we should be finding some others. So here you can see the others entry, and now the first column, or in our case, the first transformation is successful. Now comes the department part. Similarly, you can go ahead with the replace values option here. And in this particular option, we need to write down uppercase null. And let's imagine any new employee, let's say our requirement is in engineering. So any new employee which has been recruited will be provided to engineering department. So I'll write it as engineering, or it could be product management based on the requirement, right? And I will click OK. And the next replace value function is also successfully done. And this is simple, right? This is our imagination. But in case if it is a little complicated, let's say any employee that was recruited in the month of March 2025 should be for marketing, and any employee which was recruited in the month of May in 2024 should be for business development, right? You can also do that. You have the operation called add column based on a condition, and you can provide the conditional column and then move these employees to a dedicated team. And that's a lesson for the next session. Now we have another column, so let's quickly go ahead with that. In here, you have null values as well. So instead of just replacing these null values with some random data and making it complex, since it automatically took it to a float value, here you can see the fourth step, right? So let's not do that complication, but instead what you can do is just quickly apply a filter and unselect null, so that all the employee details which are no longer working with this particular organization are erased. Not erased totally, just filtered out basically. So now this was the thing. Apart from that, if you wanted to, the next operation is about extracting the country. So now the fun part. So go to add column, and here column from examples. Now here it will ask you two options, from all columns, and the second one from selection. So we want to go with the selected column. So we'll go with the second option, from selection. Now it's your duty to train Microsoft Power BI, your thought process, the way you're thinking. So If I go into this particular cell and I write USA, it understands, okay, he's trying to extract the country USA. Automatically, wherever it finds USA, it has extracted USA. It's still in process. Now I come to the row number 3 and I'll write NZ for New Zealand. It understood NZ, and here you can see the highlighted row number 6. It has written some ELS, but ELS is not my expectation. So what I'll do is I'll quickly rewrite this as USA. It might take a few iterations, but not more than 6 or 7. It should, like, normally 2 to 3 iterations will make Power Query understand your requirement. So you can just eyeball everything, and once you're happy, I think we have about 1,000 entries here. So 1,000 entries are good enough, and all the entries have successfully extracted the country. And you can just click on OK, and your new column has been successfully added. You can also rename this particular column as country PRY. There you go. So your new country is successfully added. And in case if you don't want this, you can eliminate it. But in case if you want to continue having this address, you can keep it. So for me, I don't want it right now. I'll feel free to eliminate it. And you have a good amount of data. And in case if you wanted to go ahead with, the separated column for year, you can also do that. So you just need to go the first column, which is start date column. You can select the column, and here you have the date option. So what you can do is year. Select the year, and a new column which is dedicated for year has been successfully added for you. So your data is almost ready for analysis. So what you can do here is you can just go back to the home option, and here you can choose to close and load the data. So there you go. You have a completely filtered and purified data ready for analysis. In the same way, your data will be loaded to Power BI as well, and you can go ahead with visualizations part. So on the flow, in these next upcoming sections, we will also go to it, where we will load the data directly to Power BI, and we will start with explorations as well. And we will also create a wide variety of charts, column charts, bar graphs, pie charts, donut charts, and a lot of options which are available. And apart from that, we will also create a highly interactive dashboard. As discussed before, we will be having sales data sets, and we will be working on the first current 5 years of data sets. And then we will also add a new data set of the upcoming year or the current year, and then we will just refresh the dashboard, and automatically it recognizes the changes, and it will load the data, and you'll have a fresh data set or dashboard which is completely interactive. So there are a lot of things which can be done. And here on the right hand side, you can see the query options. If you click on that, you can see you will be back on the Power Query window, and you can see all the steps that you have applied. And in case if you want to change anything or if you want to remove anything, you can feel free to just click on that cross icon there, and it will remove that. So that's how it works. Now you can close this particular query settings and go back to the dataset. And in case if you have any connections with other datasets as well, you can establish that connection with your datasets, and it will be good to go. And you can also include this particular data for creating a pivot table as well, which looks something like this. So let's select all the data, which is completely clean and ready for execution. You can go into the option which says pivot table, and here you can choose a new sheet. This is how it looks like. So you can choose to go with a new sheet, and you have a pivot panel ready for you. So what you can do is maybe drag and drop department into rows, and then you can also include salary, and now you have how much salary are you paying to each department. And apart from that, if you wanted some a little more detail, you can also drag and drop the name row to values. So you have the count of employees in each department. So you can see product management has almost highest kind of number of employees, and you can also choose to kind of sort this just like you do in regular Excel. You can choose this particular table, and then you can sort based on increasing or decreasing order as provided here. And apart from that, you can also choose to add a date or year here, So year to columns. So you have a side-by-side approach of 2024 data and 2025 data, and all the details of the employees and the salaries, everything, right? So this was the first approach, and you can name this as pivot table, right? So this was the first approach of loading data from an Excel file. Now let's go with the second approach, where we wanted to get the data from a web page. So I'll close this Excel file. You can choose to save, and let's also save the previous one. This can also be saved as a reference file. I think I saved it previously already. Yeah, there you go. Now we have opened one of the web pages, and I think Power BI is also open. Not a problem. You can close this. Don't save anything. Yeah. So we can choose any of the open source datasets. So before you go ahead with web scraping, understand this fundamental rule. So there are many websites out there. It can be based on cryptocurrency websites. You can also know where the current value of a Bitcoin or any crypto coin, right? So such websites, they have some security concerns. That particular data is not available for open source, right? So most of the times when it comes to data analytics or business analytics perspective, web scraping is very rarely done. But from organizational level, web scraping can have a little bit of room for it. So there will be websites which have a dedicated log for them, so they don't open source their data for public users. And there are some websites which are open for everyone. So based on your choice or based on your requirement, you can go ahead with the web scraping option. So in my case, I'd like to go with some open source learning pages like Wikipedia, something like that. So I'll type Wikipedia, American population or Indian population demographics, such datasets. So let's go with this one. United States territories by population, or the first one, demographics of United States, right? So here we have some data tables. So here we have median males, females, total population, country, and yeah, this is year-wise data. And here we have rank, name, side-by-side approach. Yeah, this one is also good. Year-wise, average population, live births, deaths, and all those. So you can choose any of the web page that you feel comfortable to work with, or based on the requirement, if you receive any of the dedicated link, you can go ahead with that. So the approach is simple. So I think this particular data looks good. So here we have, state, and then census population, and largest cities, etc. So I'll go ahead with this particular web page. So I'll copy the URL. This is the first step, and go to Excel. Once you reach to Excel, you can create a new workbook, or you can choose to go with the reference workbook as well that we created previously. I chose to go with the new workbook, and here we go to the data option. So it is completely similar in Power BI as well. So we are doing this for learning purposes on Excel, and once we're comfortable, we can go to Power BI. So since Power Query has the same interface on both Excel and Power BI, it's comfortable to go with Excel as well. I think I closed Power BI. Yeah, so blank. And here you have the get data option. So here you can choose the option which says web. You just need to simply, okay, cancel. You just need to simply drop the URL and it will load the dataset for you. This is the one. You can simply place the URL and click on OK, and it will open the Power Query window for you. Similarly, while that happens, you can choose the get data option, and here you can provide from database, Azure, others. Here you have the web option from web. So if you are applying this for the first time, you might get a few options where you have to choose basic or advanced or based on the requirements. I've done this a couple of times. So it will just directly take the request and load the data for me from Power BI or Power Query window. So this is the one I was talking about. So access web content. So here is it asking for anonymous, Windows, or basic. So you can choose anything based on your requirement. If it is basic, you need to provide some credentials. If it is Windows and you need to provide the current credentials of your Microsoft account, I would like to go with anonymous for learning purposes and connect. And slowly the Power Query will be starting for you. So meanwhile, let's also check on the Power BI platform. So here you have the preview. So it's completely similar on Excel as well as Microsoft Power BI. So you can just go to the view option. So this is the first table. So here we have columns and rows. So here you can see some values. So if you go back to the dataset on web page, here you can see some aggregations of, not aggregations, combination of the first two rows. So the first two rows were combined and named as state or territory. In the same way, here you can see the preview. Null value is placed in the first entry, right? And some naming conventions are gone wrong based on the web engine here. So here you can see some links, right? So some links are attached to this particular table. So what Power Query did is it considered this as a data entry, and this particular elements are also visible on the Power Query window. So you have the complete authority, and you have the complete options to rename the columns and eliminate the first row, right? You can do some changes on that. So let me close this here and go back to Excel. Let's see if that got loaded. Yeah. So here you have the select multiple items. So you can choose to select multiple tables you want to go ahead with, or if you want to go ahead with only one, like we discussed. So we can also go ahead with only one table. So you can quickly have a preview. So if this is the one you're looking for, since we had a lot of tables in the original web page, right? You have a table over here. You have furthermore, if you scroll down, you have one other table here, another population states table here, right? A lot of tables. So you can go through all the tables, preview, and select the one which you're looking for. So this is the one I'm looking for. So what I'll do is go to the transform option, and now it will open me the query window. So just like we had before, left hand side will be for queries and right hand side will be for applied steps. And similarly, it shows the liberty to do some changes for us. It promoted headers, changed data types. So I want to take the control for myself. So I'll remove the change data types and also promoted headers. So far so good, not a big problem with the headers, but we always have the option of renaming, right? So now let's rename this particular column header as census population _1, and this one as well. So we can go with rename. So this could be census population _2. Largest cities is good enough. Largest cities 2 is good enough. House seats B. Okay, why don't we name it as A? Or I think since house seats is good. Now this will be B by default. Let me remove this. There you go. You can also vote. So rename votes to population percent votes in 2020. And this can also be renamed. So this is simple, but we are doing it for multiple times so that you have a quick understanding. You have a grasp of how to continue when you're on your own. So here you have percentage of US in 2020, percentage of EC in 2020. And now so far so good. Now, remember the option that we were discussing about removing rows and columns? So here you can see some irregularities in the first column or first row, right? So here you can see largest cities. Okay, I think this can be named as city name, right? So rename it as city name and city population so that it is a lot more easy to understand, right? And seats could be good. Our seats percentage null, right? So far so good. So what you can do is choose the remove rows option, and it will ask you the options, top rows and bottom rows. Based on your requirement, you can go ahead with that. So I'll go with the top rows, and what I will do is, it will ask me how many number of top rows you want to delete. Let's say I have problem with the top 2 or 3 rows. I can directly specify the number as 2 or 3. But now I have only problem with the first row, so I'll provide the number as 1, and automatically the first row will be eliminated. Again, when dealing with such web extracted data or web scraped data, you need to be very careful about the steps you're applying, right? Now, for this scenario, we have changed some column names and all of those things, but tomorrow the columns might be rearranged. For example, here you can see state and territory. Next one is census populations, right? Instead of state and territory, you might have city name, right? The columns might be swapped, or maybe for the next time, the hyperlinking on the data table may not be done, right? And also there is a good chance where the dates, right, July 2024, April 2020, city names, city population, there might be slight changes to these, right? So this type of operations, when you're dealing with web scraping, you need to be at most careful with what are the steps you're applying. Mostly these are not preferred in real time in business perspective or data analytics perspective, but on the organizational level, very rarely this will be done, but it can be a long time consuming process. But make sure that you're applying all the steps that you are considering. Now, if I see all the data set ready for me. Now what I want to do is I'd like to select a few columns and run my analytics. So we have the choose columns option over here. So I'd like to choose the columns of city name, city population, and maybe population percentile of vote, and OK. So out of 3 million people, only 720 or 732,000 people chose to vote, or maybe some miscalculations in the voting terms, right? So let's go with the analysis part of it. I'd like to go with the population city. And if you're comfortable with the data set that you have, you can choose to close and load. There you go. So the queries, connections, extremely similar to what the process we made previously. And you have the option of forecasting, right? So in the current year, this is the population and what could be the future population. You can add a quick, forecast data for your data set. And apart from this, you can select this particular data set, and you can choose to go ahead to Power Pivot, and here you can insert a pivot chart. So you can go ahead with any of the charts available, and you can have a demograph of all the charts. And that was part 2 of loading the datasets. You can quickly choose to save this file, and let me save it as reference 2. And now will be our next part. Now, so far we are done with the web import of data. Now let's go with another part. Cancel. We don't want to close Power BI yet. So the other part will be where we will be processing some appending and merging operations, which are completely similar to SQL joins. So this has been saved, so I'll close this. Save and close. I think we have a lot of states there. That's the reason bar chart was not showing any data. Not a big deal. So just for learning purposes of web scraping, we did that. So now I'll start a new workbook altogether for the third reference part. So the third part, initially we did Excel, then we did web scraping. Now we will be doing the appending and merging operations. So this is the fresh workbook. So again, we need to go back to the data option. So we will be loading the data from file, and again, Excel workbook. So this workbook has multiple files in it. So that's the overall approach. where we will be performing year pending operations. So we'll be in data sets, and this is the one, students and courses, right? We will load it. It might take a little time, but not to worry. Yes, there you go. So you remember the select multiple option we discussed before? That's the one. So we have courses, so we have years as well. So now we will be transforming the data. So now we are on the Power BI's or Power Queries window. Now, so this particular table is the courses table. So we have some random courses here, the respective teachers, lesson type is it practical theory or internship. Then we also have credit score like 1, 2, 3, so 4, so on. And we also have assessment type, which type of assessment did they face? Was it a quiz type assessment, continuous assessment, return or project work, or was it oral assessment, right? Just something like that. And then we have year 11 and year 12. So these are the students in year 11 and these are the students in year 2. So what is the main purpose of this particular attempt? So in this particular attempt, as you can see, we have students, their gender, their course, and we also have courses. Now I want to know which particular student has taken what course and who was the dedicated professor or teacher and what type of lesson are they receiving. Is it practical theory, internship, anything like that? And then what are their scores when they write an exam or when they have a oral exam? Then what is the number of marks that they have achieved in what format? I want to know that. But here all I can find is student name, gender and course, their marks or the grades that they have received, what type of lesson did they receive or what type of assessment did they face, who was the teacher. These details are not available in any of these tables. And again, we have two different tables here. One is year 11, another is year 12. Now, how do we do that? That's the question, right? That's where the home ribbon has two options, merge and append functions come into the picture. So automatically it changed some data types. So here you can see only applied steps, and here as well it has changed a few things. And when it comes to courses, so credits, it took the changed data type, it automatically made it to a whole number. That's great. Now we need to combine both year 11 and 12. So for that, I'll choose year 11 and go to merge queries. And after that, I think we were supposed to go with append queries, not merge. Merge is the next step. So two tables. So you can choose two tables or more than two as well, three or more. For now we have just two, so we'll go with the two tables option, which is default one. So here you can see we have year 11 as current. So that means we are currently in year 11 table. So I want to connect or append the data of year 11 with year 12. Then press OK. And now you have all the data of year 11 and year 12. But there is a small bottleneck. How do I identify which student belongs to which year? Okay, and also I think we missed out on the column headers. So in such scenarios can be reverted, not a big deal. So what you need to do is just click on the cross sign here to remove that function. And now what we will do is we will do some changes. So select the dataset and then click this particular option which says use first row as headers. So this is the fundamental thing which you need to remember. Always check the column headers. Once you're satisfied with the column headers, then you can go ahead with the rest of the process. Now this was step 1. Now what I want to do is add a dedicated column which says this particular column is data related to year 2012. So I'll add a custom column. I'll name this as year, and within I want to add a text based input here. So within the double quotes, I'll add year 12 and press OK. So this is automatically, okay, we need to change the data type. You can change type to decimal, whole number, percentage, text. I want to keep it as text. So again, let's try that again. Okay, there you go. Now, similar approach should be followed in this particular table as well. So we will go to a custom column. So the custom column will be named as year, and within the double quotes, we should write year as year 11. So that now we have a quick identifier which student belongs to which year, right? And again, we will change the data type from number to text. There you go. Everything is good to go. Now, if we append, we can identify which student belongs to which year, right? Now we'll go back to home option, and here choose the append queries. So append means you are attaching. Here you can see the logo. You are attaching one dataset under the other dataset, right? So click that. You have two tables, so go with the default option. But in case if you have multiple, then you can go with 3 or more tables. So let's go with 2 here. So we are in current 11. So I want to append the 11 with 12. So click the option table 12, and now you have appended the data. So if you scroll down, you can see until row number 175, we have 11 years, and after that we have year 12, right? So far so good. Now the next task is map these with courses. So for that, we might have to go to the option of merge queries option, right? So here we have course table. So if you go back here, you can see in year 11 and 12, each and every student has a course. So what is course? If you go back to SQL, there if you are merging or joining two tables, you will merge or join them based on one key, and it is called as primary key, right? So you need to have one common column or one common entry on both the tables based on which you can attach or join both tables. So in this particular scenario, course column acts as that one primary key for our merging option, right? So I want to merge year 11. So that's the one where we have all the data sets, right? So you can even rename it. So year 11. Okay, before we do this, it's better we rename this. So I'll rename this as, okay, before we rename, let's make a small confirmation. So we have both. Okay. Now we will rename this as students. Okay, we have students data table and courses data table. So again, go back to courses, use the merge queries option, and the table I want to merge with is students data table, and based on what parameter. So I would like to go with the course parameter or the course column as my primary key. So far so good, you can continue merging, but in case if you want to merge with referencing more than one column, that is also possible. So what you have to do is just hold control key and then click on the column which you want to refer it. So here in case of this data set, I'm just randomly selecting gender and teacher. But for our data set, just one column is enough, which is course, and we have selected that successfully. Now, if you scroll a little lower, you have join kind, right? If you open the drop down, you have left out the join, which says all from first matching from second. And second one is right, all from second matching from first. Next, we have full outer join, all rows from both the tables. Inner join, only matching rows. Left anti-join is about only the first join. Right anti-join is about only the second one. So the best one to be safe side, right? Even if it is a replica, you can go with full outer join. But the default one chosen by Power Query is left outer join. So I want to go with the default option here. So the selection matches 19 out of 19 rows from the first table, so it's good to go. If there is any error, you could have found it over here. And you also have some option called fuzzy matching options. So if you know what is fuzzy match, you can also proceed with this one over here. But now we don't want to work with fuzzy match. We are good with left join. So you can simply click on OK and the data will be merged. But right now on your screen on Power Query window, what you can see is just table entry. So where are the rest of the entries, right? You don't have to worry here. So all you need to do is go to the top right corner where you can see two arrow marks, one going to the left and one going to the right. So that is kind of an option which says you need to expand this particular column. So if you click on that button, the data will be expanded. Okay, now you have the respective course, the teacher, the lesson they are giving, and what is the credit score or the number of marks they have achieved, what type of assessment did they give, and who is the student and their gender, the course they took, and which year do they belong to. Everything in one shot. Now you can go to the option which says close and load. So click on close and load. So yeah, there you go. It has established connections, queries, and everything in one shot. So now you have three different tables on the right. You can see courses, students, and year, right? So the latest merge option which we did is currently in courses. So click that particular one and you have everything in one shot. So you have the course they have taken, teacher, lesson type, credit score, assessment, and everything. So now let's consider a small use case. Let's say we want to avoid people who have taken practical lesson and have scored more than 2 or 3 credit scores. So for that, how do you do it? So we have a simple filter operation right here. So you just need to click on the filter operation. It is taking a moment. So you can go to home and apply a filter. There you go. Now you can click on the filter, close this. Or I'll do one thing. I'll create a fresh new sheet and then paste it over here. Courses. And here I'll be pasting it. There you go. Now we have a shortcut if you remember. Control Alt H O I. Undo that. Alt H O I. For adjusting the row width, and you have successfully adjusted the row width. Now these are your columns and rows. What you can do is quickly apply a filter and you can segregate your data. So I want to choose practical. The filters are not loading for some reason, but basically that's how you do it, right? So you quickly apply a filter. Okay, let me delete this. For some connections, I think it is unable to load properly. So let's try that again. If the filter is functional, I can see the filter getting loaded, but for some reason it is not staying on the screen. Yeah, so basically what you can do is, let's try to create a new sheet altogether without any data connections. Now we will select all the columns, Alt H O I to adjust the width, apply a filter. I think this should help. Yeah. Yeah, basically what you can do is apply a quick filter, select the filter option, and in which you will select practical, and here you will apply a condition where filter condition will be credit score should be greater than or equal to 3 or 2, right? Based on that, the data will be filtered. So for some reason I can see the filter, but it is not staying long enough on the screen so that we can apply it. Could be a small technical error, but that's how you basically do it. And that brings us to the end of module 4, where we have learned the basics of Power Query, how to clean the data, how to split into columns, and how to do some basic functionalities like creating an additional column which extracts the data from a logic based on your thought process. And we have also done web scraping. We have considered the Wikipedia open source data sets to do that. And now we have a comfortable understanding of Power Query in both Power BI and in Excel. Both the domains are one and the same. So in the upcoming modules, we will be learning data modeling, DAX calculations, data visualizations, and creating a completely interactive dashboard, which includes slicers, filters, and a lot more. Now, let's proceed to the next module. Welcome to the module 5 of this Power BI full course. So, module 5 will be about the data modeling in Power BI. So, what exactly is data modeling? Imagine you had a store or some online website where you sell some products. So you have shipment data, product data, geographical data, and the sales team data. And apart from that, you might also have calendar data, which is really vital in business analytics. So all the tables are interconnected. So one, which is the shipments table, will be connected to the product table, also to the orders table, sales team table, and the calendar as well, and also to the geographical location, right? It's like the shipment data table is in the middle of all the other tables. It's forming a schema, it's forming a shape, right? So this is data modeling. It might be a little confusing, but don't worry. To have a better clarity, we will go to an Excel dataset so that we have some detailed understanding of what exactly I'm talking about. We'll also deal with the fact tables, dimension tables, relationship between all the tables, and how exactly a data schema is made. And then we will also do some sample visualizations using that particular data model. Now, let's go back to the Excel dataset. So now we are on Excel dataset. So we have shipments table. So we have dimension data and also the calendar. Now, when we come into the shipment table, we have shipment ID, SPID, PID, GID, ship date, amount, the number of items, and order status. So we will look into each of these columns. So the shipment ID is a unique ID for each and every shipment that you made from your website or your inventory. And SPID is the sales team's ID on which this particular sale was made. Who was the person who was the one who is authorizing this particular sale and who took care of the rest of the process. Then we have PID, which is product ID, which product was sold, and the GID is about the geographical ID based on which geographical location was the order placed from or delivered to. Then we have ship date, based on which date was the shipment made, what's the amount and the number of units sold, and what's the status of the order. Is it delivered, or is it in transit, or is it shipped, right? Some details of that. Now, what are SPID, PID, GID, and ship date? How are they related to shipment data table? That's our next approach. So here we have the dimension data. So in dimension data, we have 3 tables. The first table is the product table. What products are in our inventory, what category they fall into, what is the cost per unit, and what is the PID. So basically this particular table, the entire table, has to deal with one item, which is about the products item, right? Now here you can see the fourth column, which is stated as PID. Now PID is the primary key which can be used to connect the product table to the shipment table. There is one connection established successfully. Now let's go into the second table. So the second table is nothing but the geographical location table. So here we have a geographical location: India, US, Canada, New Zealand, Australia, and UK, and also the regions: APAC, Americans, APAC, Europe, etc. And here we have the third column, which says GID. Now this particular GID acts as the primary key which combines the shipment data with the geographical data. So here we have the GID and the shipment ID. So this particular table deals with the geographical location. Now going forward, we have another table which says about the salesperson or the sales team, right? So here we have salesperson who is responsible for the sale, and here the team to which they belong to. And third column is the SPID, which combines the shipment data table with the salesperson data table. So this is the SPID we were talking about. Now, apart from these 3 or 4 tables, including the fact table, we have another table which is called as the calendar table. So this particular calendar table is nothing different to your regular calendar. It has all the dates, all the months, all the weekdays, and the year table, right? So this is like a calendar. So whenever there is an order or shipment made to that particular date, we will have a registry here. So that is how the calendar table works. Now, here in the shipment data, you have the ship date. So this particular ship date is connected to the calendar table here, right? Now we have all the 5 tables as per the discussion. Now we enter into the schema, the star schema, which is one of the most popular schema used in the current world of business analytics and data analytics. So here you can see this particular table is the fact table. Why is it called the fact table? Because rest are the dimension tables which deal about the people. So it might be the customer data or it might be the salesperson data. So basically any table which has the details related to customers or the salesperson is one dimension table. And the other table is the product table, which solely deals with the product details. And the other one is the calendar detail. So this particular table wholly deals with only the calendars. And the last one is the location table, which only deals with the location details. So all these people, product, calendar, and people data tables, which uniquely work on one single aspect, are connected to the fact table, which maintains the details of all these tables. Let's say I want to find out, if we go back to shipments table, I want to find out the details on this particular shipment ID, which is 058. So what is in 058? Who was the person who made this sale? What product was sold? To what particular location? And how many orders were placed? What is the status, right? All these details are not available here, but instead of that, we have the SPID. So if I explore the SPID, I will get this particular entry. So this person was responsible for that particular sale and he belongs to this team. And if I go back, here I see P01. So what is the product? If I enter P01, I have this particular product and this particular category, and this was the cost per unit, right? And again, if I go through the GID, this is geographical data. So GID 3 is Canada and the region was Americans, and this is the location where the shipment was sent. And now on what date? It was 28th of June 2024. So here I have that details as well. June 28th, right? And at last we have the total amount paid, the total units sold, and the status was delivered, right? So this is how each and every table is connected to one another, right? So shipment table falls in the center location, and all the rest of the details, which is calendar, people, product, geographical location, all are connected to the shipments table, which is the fact table, and rest of the tables which surround the shipment table are called as the dimension table. Now this might be a little confusing still, but don't worry. Now we will close this particular data set and head back to Power BI so that we have a comfortable understanding of what exactly I was talking about. So now we are on Power BI. Let's create a blank report and let's load the data from Excel. And here I have the sample sales data. So I'll open this. It might take a little while, but don't worry. So there you go. So this was the sheet 2 where we created the diagram. Don't worry about that. Now we need calendars table, locations table, people's table, products table, and the shipments table. So shipments is the fact table. Calendar, locations, people, and products are the dimension tables. Now, this particular data that we have is fine. We don't have to do any data cleaning. This was previously cleaned and processed data. So we can directly load the data from this stage. So let's click on the load button, and it will take a little time to load all these data models to Power BI. So there you go. You can see calendar, locations, people, products, and shipments are loading. And you can also read creating connection in model. So data modeling is already happening. So detecting relations, 670 rows loaded successfully. So on the right hand side, you can see the data, right? If you scroll down, you can see calendar, you can see locations, people, products, and shipments, right? So these are the basic entries that we are having. Now, what are we talking about data model since so long? So here you can see the report view, data view, or the table view, and this is the model view. So if you click this, you will now understand why we made that diagram on Excel spreadsheet. So here, let me close this as well. So here you can see how the products table is related to shipments table, and how locations table is also connected to shipments table, and how the people's table is also connected to the shipments table, right? They create a star pattern, almost a star pattern, right? Now you can see a star logo here, right? If I expand, and you can see one number here. So what this specifically means, this is many to one relationship, right? Many entries of shipments table are related to one element of this particular people's table, which is SPID. Remember the analogy we discussed? That's what it is. So here, many entries of shipment table are related to one entry of locations table, which is GID. Similarly, we have the many to one relationship here as well, where many entries of shipment table are related to one entry in products table, which is PID. Now, the only data which is not connected still is the calendar data, but not to worry, we can connect that as well. So here we have calendar date and here we have shipment date. All you need to do is click and drag this particular element to calendar date and you can establish a connection. Now, here you have a new relationship. So Power BI is showing you this kind of relationship can be established between the two tables. Now you need to cross verify of the elements you're choosing, ship date and calendar date. Once you're satisfied, you can proceed, and here you have by default many to one because Power BI's model was able to identify which kind of relationship can be established here. But in case if you're not satisfied, if you want a different approach, you can also move the cardinality from one to one to many, and many to many. By default, it is many to one. Let's keep it that way. And you can also go with cross filter direction, which can be single or both. For now, single is enough and single is the one recommended. So let's keep it that way and save this, and you'll have a relationship with this particular element as well. So multiple elements of shipments table is related to one entry, which is calendar date in this particular module. Now let me lesser the size. Let's zoom out and zoom in. So that's how the relationship looks like. Now apart from this, you also have properties, which helps you understand what kind of relationship has been established between any two tables here, the cardinality, and you can also manage relationships here. So here the shipments GID has got many to one relationship with locations, and shipments has many to one relationship with PID, and shipments ship date has many to one relationship with calendar, and shipments SPID is collected to SPID in many to one format as well. Now you can close this, or you can also add a new relationship or edit an existing relationship or filter any of the relationships present here. Let's close this for now. And apart from this, you can also create a new calculated measure, new column, new table, calculation groups, and you can also manage the roles, view as, right? Basic functionalities. Now you also have the data details here, data model. So you can go and take a tour. Now let's close the model view and go to the report view, where you can create sample charts. For example, I want to know the geographical location, or we can also go with the Q&A visuals. If you double click, the Q&A will start here and you can just simply type what are you looking for. I want to know category wise sales in region, geographical region. Category, sales, region, and the type of chart could be bar. Now you just wrote simple English language and the Q&A is trying to understand what are you looking for, and it will try to generate a visual for you. Or you can give it a moment and try to do it all by yourself. So I would like to go with bar graph, or you can go with the pie chart as well. And now what you can do is add geographical location. Since we're dealing with geo, why should we not go with map? You can also go with map, but that's not nothing to worry about. So what you can add is you can add this here, and you want values. So I want to go with the summation of amount, order status, monthly status, total sales. So I want to go with summation of amount, and it will be added in values. So here we have a readily available visual. So we sold about 23% to UK. So you can also add tooltips. So I'll add geo to tooltips. And in India, we sold about 23% of the sale, and in USA we had 17% sale, and in Australia 17.47, something similar, and in New Zealand we had 12% of sale, and in Canada we had about 5% of sale, right? So apart from this, you have a wide variety of other visualizations as well, like slicers, funnel charts, cards, and a lot more, which we will be exploring in the upcoming modules. And with that, we have come to an end of this module on data modeling. In the upcoming modules, we will deal with DAX calculations, basic visualizations, and building an interactive dashboard. So now we enter our next module where we will learn the DAX expressions. So DAX stands for Data Analytics Expressions, but for some reason, instead of taking DAE, they took DAX. And simply, the same DAX is also as complicated as the naming convention. So we will have a lot of, let me cancel this. Yeah. So we will have a lot of naming conventions in DAX, and also we'll have one common misconception if you're a total beginner, or if you have transferred from Excel to Power BI or any other platform to Power BI, then obviously you'll definitely have a small misconception that DAX is all about some basic aggregate functions like sum, average, mean, median, standard deviation. But it is a part of that. Apart from just being an aggregate function, DAX has a lot of other things to deal with. So in simple terms, DAX provides you a lot of freedom when it comes to deep diving into data analytics. You can kind of write your own mathematical logic. If you understand your business requirement, to be honest, before you dive into DAX, you need to understand what is the business perspective of your business owner. If you are the business owner, or if you're working for an organization, then your organization's business perspective, you need to have a good stand on that. You need to be able to understand what your business owner or you as a business owner is expecting from your data, right? Once you have that particular clear vision, you need to extract the data and clean the data. Unless you have a clean and perfect data, writing DAX would always end up in miscalculations. Let's say for a simple example, if you wanted to divide a certain column with another one, if you had zeros in it or null values in it, obviously if you're directly dividing column A by column B using a slash, then definitely you'll end up into zero errors, right? The error that you get divide by zero, correct? If you change few things in the same division function, instead of writing a slash, if you write divide and the column name, comma, column 2, then you might not end up with that zero error, right? Divide by zero error. So few minute things you need to keep into consideration when you're dealing with DAX. That's one thing. And apart from the regular average or sum or aggregate functions, there is a lot to deep dive in measures and all the DAX functions. So with that basic understanding, let's dive into the DAX functions. Now let's create a blank report, and here we will be working with the same dataset that we worked on the previous section, that is the sales example dataset. So we will be having the calendar, location, people, products, and shipments. Let's give it a moment while the data loads. And apart from just the datasets, I would also highlight or some important things about the data modeling here. So when you're always working, just keep always this thing in your mind. When you're working with DAX, you need to have a good organization of your schema or the data model. Yes, previously we discussed that star schema is one of the most frequently used, or one of the most important schemas out there when it comes to data analytics. But when you're especially working with DAX, then make sure that you are using star schema. But along with star schema, the arrangement of data sets or the data models is also important. It plays a very critical role. It kind of gives you a skeleton how the data is flowing and what it is happening in the background. So to understand this better, let's actually dive into the data model. So I've selected my tables, which is calendar, location, people, products, and shipments. So we want to go into transformation, or you can directly load. You don't have to worry about any kind of data errors in this. This is actually a cleaned data set. Since we are working with DAX, I made the cleaning and everything is good to go. So I'll directly press the load option here. And let's give it a moment while all the 5 tables load. So you can see creating a data connection in model and loading the data to model, relationships established, and all the rows are loaded successfully. Now, before we go into actual DAX, we should have a quick look on the model. So here, let me close data, let me close properties. So here you can see our fact table has been located in the center position. So let me reduce the screen size a little bit so that we have a quick overview. So whenever you're working with DAX, make sure your tables are arranged in this way. So for example, this is a dimension table, right? So dimension table should be all arranged in the top position. So we'll just give it a moment. So this is our calendars table and this is our products table. And this particular fact table will be arranged here, right? So now why did we do that? You will understand which of these data tables or data models is a fact table and which is a dimension table if you go ahead with this type of arrangement. So this type of arrangement, just by a visual glance, you can understand which table is what and which data model is meant for what purpose. So make some quick arrangements so that you'll have a quick overview of what exactly you're dealing with when you're working in real time. So here we don't have an established connection with the shipments fact table with calendar. That can be done in a moment. Just go to that one element which can relate to your calendar. So we should be having ship date. Yeah. So just like we did before, drag and drop ship date with the calendar date here. You'll be having a new relationship and Power BI will identify which are the columns which can be related here. So you can see it automatically selected ship date and the calendar date. And you can also see the cardinality. So let's go with the same cardinality by default provided by Power BI. So we have many to one, one to many to many, and one to many. So whichever cardinality suits best, you can choose that and go ahead with it. By default, Power BI has the caliber to select the best one for you. So I'd like to go with the Power BI's choice of cardinality here. And anyways, this is the one which we're looking for as well. So you can quickly save and you will have a well-established relationship between the calendar as well as the shipments table. So all the tables, let me expand this. So all the tables located up top are your dimension tables and the table which is located here is your fact table. And here you can see the relationships processed. So here it is many to one and all the other are also many to one. And if you expand this a little bit more, you can see the flow diagram here. It is flowing from the dimension table to the fact table. It means it acts like a filter. Let's say you wanted to filter out something from the locations table. So we have about 5 to 6 geographical locations and 5 to 6 geographical IDs. Let's say you wanted to know the information for a specific geolocation and you wanted to identify all the shipment track records for that particular location. So what this majorly does is it acts like a filter and it filters out the details for that particular geolocation. And similarly, the facts table will also change. It will only show the rows related to that particular geo ID only, not all. So similarly, here you have salesperson details. If you specifically provide a dedicated salesperson, the same filter applies and the data will be filtered let me drag this. So data will be filtered and accordingly the changes will be done on the fact table as well. Now that's how, or that's the reason why we need to arrange the data models in this particular module or this particular style, so that you can identify which table is a fact table and which table is a dimension table. So I hope you had a great understanding of that. Now let's go back to the report view here and you can get started with DAX. So there are multiple ways, since DAX is very critical and an important aspect of data visualization with Power BI. Microsoft has chosen to add multiple ways to select a DAX operation in Power BI. So here we have one option, which is DAX query view. You can directly access DAX from here as well, or you can choose to dive into modeling. And here also you have the calculations aspect or calculation style here. You can choose to create a new measure or create a quick measure. So nothing major difference between new measure and quick measure. So quick measure is the easiest way to create DAX or a measure which happens to be an aggregate. So if you wanted to create an aggregate function like sum of all the sales happened or the average of sales happened, you can choose those quick measures or quick aggregate measures through quick measure here. And if you wanted to dedicatedly write a DAX, then you can choose the new measure from here and write your dedicated DAX function. Apart from this, if you go back to home, you have another calculation tile right on the ribbon, right? You can choose to go ahead with new measure or the quick measure from here as well. Apart from this, there is a quick shortcut as well. If I go into shipments and wanted to write a measure, I can also do this from here by right clicking on amount, and you can see we have a new measure or new column option here as well. So which is also one of the options to create our DAX. So with that, we have a basic understanding of how exactly DAX works or how exactly you can navigate to DAX. Now, whenever you're dealing with DAX, you'd better, if you're new to DAX, then I'd recommend you better go with a table visual so that you'll have raw numbers and you can understand what exactly is happening on the go. Now, to understand DAX better, let's start with the picture which we already have in our mind. DAX is just aggregate purchase. So let's get started from there. So on the go, you will understand how it actually differs from our picture that we have in our mind. So if you're coming from an Excel background, then definitely you might think DAX is just another aggregate function, but it's not. So it's a lot bigger and different from that. So for having a comfortable understanding, let's anyway start from that particular aspect. So let's try to create a DAX here, which will be this one, and we will have a formula bar there. So to have a better visuality, I'll expand this particular thing. So you can just hold control and scroll up and down on your trackpad, or you can also use your mouse scroller to increase or decrease the size. So if you are proceeding with DAX, then you also need to understand the syntax of DAX. And by the way, on the flow, when you're already when you've already created some DAX for yourself, then those DAX will act as your primary asset. And when you're reusing that particular DAX, the syntax might change a little bit, not too much. But anyways, let's start with the fundamental syntax. So any DAX will have three particular parts. So the first part will be actual name of the DAX, which is total amount that we have added here. The second part is nothing but this particular small logo or symbol, which is equals to symbol. And the third part is nothing but the mathematical logic that we are about to write. So let's start with that simple aggregate function. I want to use a sum of, I want to go with shipments table. So I have shipments. And here I have a shipment amount. So I want to go ahead with that particular point here. So you can either choose to write the entire name, or you can also use the tab operation on the keypad. So just click on tab and it will be selected for you. Make sure you close the last bracket and enter. So you have now successfully created a new measure. Now you might be asking me Why did I do this when I have the option of directly dragging and dropping this particular amount column from the data table? So let's also go ahead with that. Now let me add the product ID to the table. So we have added the ID rows and the total amount to this particular one. So there you go. Let me expand this. Yeah. So we have so we have the total amount here, and apart from that we have sum of amount which we created using an aggregate function. Now if I drag and drop the total amount DAX which we created just now, we will have the total amount as well. Now you might be wondering, why did we even create this? Why did we even have DAX when we already have aggregate functions available on Power BI? So this is where the point comes into picture. DAX give us a lot of freedom rather than the aggregate functions give us, right? Now, if you see, there is no difference between sum of amount and total amount here. But if you look into this particular aspect, which says formatting option, so you can go ahead with formatting. So instead of general, you can go ahead with currency, and instead of the decimal values of auto size, you can just decrease the decimal values and choose I don't want any decimal values, and then the decimal values will be eliminated as well. So I want to remove the zeros here, and I can remove those. So now you can see a clear difference between the total amount which we got from the aggregate method and the total amount that we got from our DAX method. So clearly, when anyone sees this particular number, they will automatically feel that this is currency related or sales related or revenue related or anything which is basically related to business. So it gives you a clear business point of view if you're using DAX. Now, apart from that, you can also go ahead with a lot more functionality to this, just apart from creating a total measure. Let's inspect that as well. So let me resize it. So apart from looking at this particular DAX as a similar looking language like aggregate functions on Excel, there is a lot more differences. So you might think the same sum function is also available on Excel or any other data analytics platform that you have already been on. So the difference is, for the purpose of creating similarity between DAX and the previous functions that you've already used, they are using the similar syntax, which is sum, bracket, and the shipment table name and the amount column. But deep down, it is like alphabet, right? You might have the same alphabet on your language that you're using, but the way it is being used is a lot different. So it's like you're having the template of English language to write the terms of other language. Let's say you wanted to write something in a different language like Japanese, but you don't know the script of Japanese. So instead of writing the term in Japanese script, you're writing the same term using the words of the English language, which might sound same, but the script used is different. So that's the difference between the DAX and the aggregate functions that you've already used to from the other platforms like Excel and everything else. Now, you might wonder, let's now create a new DAX and see if that particular DAX is already available in Excel or not to have a clear picture. Now, let me create a new DAX function which says count of rows. Let me create a new measure and we will name it as count rows on OWS equals to, or you can also name it as shipment count to have a better picture. Equals to count rows was a function. Yeah. So if you select this particular function, now you will be a little confused. I have never used count of rows in any of the data analytics platforms like Google Sheets or Excel, right? This particular function or a few other functions, as you can see on the set drop down here, add missing items, all except, all, no blank row, right? These are a few additional functions that you were never used to work on Excel, or they were never available on Excel. But these are some additional functions or capabilities programmed into Power BI. So we are going to use one of those. So we will be now tracking shipments. So I'll drop down shipments, and this is the measure I want to add, and enter. Now we have a new measure, and this you can see. So the major difference between any of the dimensions and fact tables here and the DAX table is you can see a small calculator logo in front of the DAX that we have created, right? So whenever you find that logo right in front of one of the data models or the columns here or the data items present here, then you should be identifying that particular entry or that particular measure is a DAX measure. Now you also might be wondering if this particular DAX measure is available in the data model or not. So or the table or not. So if you go into a data model or the table view here, if you look at the shipment table that we just created, this particular shipment table, you have all the original values, the shipment ID, shipment as salesperson ID, PID, graph or geographical ID, ship date, amount, boxes, and order status. But the measures that we created right now, we created two new measures. One was total amount and the other was shipment count. So you cannot see those items here, right? You cannot see those two DAX columns here. So it's like an added layer on top of your existing table. This particular layer can twist and turn the data. It can, kind of stress your data to extract the insights, but it will never be a part of your data table. So that's the functionality of DAX. Now, let's go back to the visualization page or the report page, as you like to call it, and try to do some evaluations on this. Now, if I drag and drop the shipment count to the data column here, I can see what are the number of shipments made by each and every employee from a person level or a product level. I think we have added PID. So from a product level, so for better clarity, I'd like to also drag and drop the product name here. So I'll drop product name. So based on this product name, I have so many sales, right? If I directly click on this particular aspect, I can reorder or we can sort this particular table. So you can see product 4 was one of the highest selling products. So we have highest selling shipment counts in this particular product. So this is the independence that gives you. Now, if I close all these things and reduce the size of my table, or here we have it. Let's try to make some space for a visualization. So you will clearly understand why DAX is so important for us and what's the freedom we are getting from using DAX. That's the one. Let us include one of the visualizations here. I'd like to go with bar graph or a column chart, whichever is functional. Let's go with this particular one, column chart, and I'll have this column chart on the okay, not this one. Let me unselect this and have an additional, yeah, this is the one. Now, if I select the geographical location and add it to x-axis and then add the shipment count to y-axis, you will have a visualization, right? Now, how is it different, or how is it making so much amount of difference? But let me uncheck this. So now you will have geographical location wise data for the total amount of sale done and the total amount of shipments done. But would you have, if you just imagine if you had used a regular aggregate functions and if you wanted to find out the details for a specific product from a specific location. Was that available for you? Unless you had a filter. Yeah, you might be telling me that if we add a filter or if we had a slicer inserted into this particular visualization, maybe we could have done it. Yes. But could you hard code it to a slicer? No, right? Slicers doesn't work that way. You cannot hard code slicers to one particular aspect. It's like a switch on and switch off kind of a tool. If you click on one particular product from a slicer, it will show you the data related to that particular one. And if you automatically switch to a different one, you cannot keep that data anymore on your visualization. But in terms of DAX, you don't have to implement any type of slicers for your visualization. It is directly hard coded into your visualization. Let's imagine I wanted to find out the total sales happening for UK region. So if I just click on UK region, I have that particular sale value. And let's say I wanted to go ahead with a specific product. Let's say I wanted to go ahead with product 4, then automatically I'll have the details related to that particular fourth product ID and the sales happening in geolocation UK. So that's the power of using DAX in data visualizations in Power BI. Now, let's explore a few more DAX functionalities in Power BI. So this particular change or this particular interactivity that you find in DAX is called as, or it can be termed as, evaluation context in technical terms. So the evaluation context here is the background process, what's happening when you're trying to filter out data without using any type of slicers or filters. Now, let's go with another type of DAX here. Let's say I want to calculate total boxes. So let's leave this page and create a new page so that we have a cleaner looking data. Now, what I'd like to do is I'd like to add a DAX function. So you can go ahead with adding new measure. So this is easier for me. You can also go ahead with clicking the right click option here and writing a DAX function, whichever suits you better. So we have multiple options to create a new measure. So I'd like to go with this particular option, create new measure. And here, my new measure will be total boxes equals to, I'll use an aggregate function, sum of shipment table and shipment box. So here you already have the table and the column name. I'll just click on the tab button, close the function and enter. Now I have created a new measure which says total boxes. I think it went into the calendar table, but we don't want it to be here in this model. We want the total boxes model to be present in the shipments table. So let's collapse all these. And now I want a new measure to be created here. Create quick measure, create new measure, and the formula will be same, total boxes equals to summation of shipments table, and the column will be boxes, close the. So the column name will be boxes and close the ampersand, hit enter, and your new measure has been successfully created, which is total boxes. Now, why did we create this particular measure of total boxes? We are trying to find out how many boxes did each product consume to pack. Sometimes you might be having a very big product, right? And for that very big product, you might have to, parcel it in terms of assembly, right? A part of the product in a box, a different part in a different box. Let's assume that you have a very big inventory, and in that very big inventory, you have one product which is bigger or the biggest of all. And to courier that particular product, you might need multiple boxes. Let's say our biggest product will need 3 to 4 boxes to courier it, right? And there is another product which is equally or a little bit smaller than that, but it is foldable or it is in a way retractable and it needs only one box. Now, we're trying to identify that one particular product which is consuming a lot of your inventory just for packaging, right? In that particular aspect, if you find out that particular product, you might be looking for an alternate so that it saves you on packaging. So that's the business point that we are trying to deal with here. So for that, let's drag and drop, or let's create the same table vision for us. So we'll have a table here and we will drag and drop product ID or product name into the table, and then the recently created DAX, which is total boxes. Now you can identify, you can see, or if you rearrange it, we can see product 4 is that one particular product which is consuming a lot of boxes to courier, right? And let's also see the total amount it is getting us. So let's have total amount here. Now you can see it is earning us about $33.2 million with such amount of boxes consumed. And let's rearrange this. So if you can see, we also have product 22, which has, okay, let me expand this a little so that we have a clear picture. So here you can see, earlier we shows product 4, which was giving us 32 or $3.2 million with using the highest number of boxes. But here, comparatively, 1/4 of total packaging, we have the most highest profit from product number 22. Now here, what we achieved is, we need to identify which is product 4, and we need to look for alternatives so that we can save a little bit of money on packaging and couriering the product, right? So this gives you a clear picture of business aspect that you must be looking into, right? DAX is the one which gives you this freedom or this level of freedom to identify and execute some business decisions. Now that we have understood the reason for this particular freedom, let's dive into the next aspect of today's DAX, which is DAX reusability. So this will take us back to the point 1 where we discussed about the syntax of DAX, right? So we initially thought the syntax would be different, right? So we will be having a DAX name, the second part will be equals, and the third part will be the table name and the column name. Now comes the part where we discuss the differences, right? There will be a little difference in this particular approach where we will be reusing the already built tags. Now, you can also go ahead with the standard procedure of using the table name and column name, but the reason for not going with the standard way is different. So this gives you an advantage, an edge to identify which is, so we have two types of functions. Basically, whenever you use an aggregate function or the function that Power BI provides you, that particular function is called as the implicit method, and the one you specifically write is called as the explicit method. So when you are using a calculated DAX for recreating a new DAX, then you will identify this particular method is already an existing DAX and it is a measure. And in case if you're using a table name, that means you're using a specific hard-coded table name. That helps you differentiate between these two approaches. That's the reason why we don't go ahead with the standard approach of using table name and column name when you're trying to reuse the existing DAX measures. For example, let's go ahead with identifying which box had more boxes per shipment. So here we had created right total boxes and total amount. So for identifying boxes per shipment, we will create a new DAX. So let me expand this. So let's create a new measure. And we will call this particular measure as boxes per shipment. So it's similar to the previous approach or previous calculation we did. So boxes per shipment can also be calculated by using total boxes. We created a total boxes thing here, right? You can drag and drop this particular thing here, or you can total boxes. So the key identifier that if you are reusing a DAX or if you are reusing or using a column name is this. If a formula starts with box bracket, then or square bracket, that means you're using a DAX. And if you are using the normal parenthesis, then it means that you're using an existing column. So total boxes divided by shipment count. So shipment count. So this is the one. Just tap to enter. Now you can close the parenthesis. I think we did not create a parenthesis in the end. Okay, that's fine. press enter and your new DAX or the DAX which has been created by reusing the existing DAX is created here. Now what you can do is you can drag and drop boxes per shipment and identify maximum boxes per shipment. So if we rearrange this, just click on this particular aspect and you can reorder. Now you can see the product number 18 actually used a lot of boxes per shipment, right? And the initial aspect where we identified total number of boxes. So yeah, I think now we have a clear picture. Previously, we misunderstood that the total number of boxes used by product 4 were highest. But when the final packaging comes, there is a possibility where the exact number of boxes could be a little different, right? One huge box might have smaller boxes inside it, right? It's like an abstracting process where you package every minute item into a small box and all those small boxes will be packaged into a large box. Now this particular thing, what we have here, gives us a better advantage. Now you can see obviously 4,80,000 or 480,000 boxes were used to package product number 4, but at the final count, it is using 753, which is a lot closer or a lot similar to product number 18, right? So here you can see a minute difference between the two packaging. So that is the level of detail we can get into by using a little bit of DAX for business purposes. Now, if you proceed a little bit into details, then the next thing we can calculate is amount per box or amount per shipment. So let's create a new measure, and I want to identify amount that we are spending per every single shipment. So amount per shipment is equals to, now remember the divide function we previously discussed about. If you might have, maybe there is a possibility that you might end up having 0 value in the second column, right? The column which goes under the denominator section. And if you divide such particular numbers, you might end up with divide by 0 errors. To avoid that, you can simply call a divide function here and mention the columns that you want to divide. So here we will send out 2 particular columns or DAX calculations. So total amount is the DAX calculation that we previously created. And the second value is people. So we'll be using people table here. Or I can write down salesperson. We have a people table, right? So why am I not able to identify people of salesperson? Okay, let us try that differently. Anyways, we have the amount spent per packaging here, but we just wanted to explore a little bit of DAX reusability. Let's try to hard code that. So under people's column, we have PID. Salesperson. Okay, let me try this particular approach. Salesperson. Still unable to identify. Let me create a parenthesis and type the table name. No news. But anyways, we have the shipment per box here. Let's close this. Let's deny this or cancel that particular DAX. But anyways, now we enter into one of the important functions of DAX. Now, this could be a game changer for you in perspective of business analytics. So that function is nothing but calculate. So let's create a new page and enter into the new page and try to create some functions, tax functions using the calculate method. Now let's say I want to identify the amount of sale did or done by each person. So for that I'll write a calculated or calculated field or new measure. So I'll go with this particular aspect. I'll create a new measure in the people's table, and the measure will be named as employee amount equals to calculate total amount, comma, people and salesperson. So previously we did not find this, but now Power BI was able to find salespersons. Some unexpected error, not a big deal. So apart from this, I want to find out for a specific person. So if we go into the tabular view, and here we have Emily Davis. Let's say I want to calculate the total sale done by Emily Davis. Study hard set, or copy this particular name and go back to report view. And where is our, this is the one. So we need to edit this particular DAX function, and salesperson is equals to, we copied, okay, I think we have everyone here. So let's erase all those. So I want to keep just Emily Davis here. So you can again come up with a new idea, or you can again come up with a new doubt where you can say, why use a filter in DAX if we already have a slicer, right? So you can do with this using a slicer, but as we discussed, when you use slicers, the slicers behave like an on and off switch. So when you switch from a different person, automatically the the control will also switch from an existing person to a different person. Now let's compare that side by side. Now this is my DAX, and I'll enter, and we have the DAX. Now what we can do is we can drag and drop product. So let's create a new visualization. So we can drag and drop product and sales done by Emily Davis, and also we can have a salesperson as well. And if I drag and drop the amount once again, so here you can see the difference, right? In the first section, we selectively filter Emily Davis, and the number is as is. And when it comes to the second filter, you don't have a filter here. You have all the data excluding Emily Davis, and everything is normal, right? So this is the main difference that we are dealing with. So apart from this, if you wanted to identify the specific number of sales done by a dedicated employee, then you can create this calculate filter for a dedicated person in a many number of ways. Now, let's head into one last approach for DAX, where let's say we have a target, and every employee has some target, and we want to find out if that particular employee has achieved the targets or not. So let's go and add a new measure, and the measure will be named as sales target. And sales target is equals to, let's say, 1.5 million. So hit enter, and we have sales target here. Now let's create a new measure. It's like an if condition. So if the sales target is achieved, then fine. If not, you mark it as not achieved or something like that. So we will create a new measure, and we will write the measure as follows, as performance is equals to if condition total amount. So total amount is greater than sales target measure. We're reusing the measures again. Then you can write it as target achieved. Else not achieved. So this will be my DAX and hit enter. So I've created a new DAX here. Now what we will do is we will drag and drop, we'll create a new table and we will drag and drop salesperson onto the table and total amount that we have done, and we will also add that performance DAX calculation that we created. And now we have a clear picture how many number of employees have already achieved their target and how many did not. For example, here you can see Carter did not achieve his target and Eva Lewis did not achieve her target, and so on. So the minimum bare number that we wanted to keep in order to find out if a target is given target is achieved or not was 1.5 million. So there are people who already kind of overachieved, and there are a few people who did not achieve their target. So there are multiple ways that you can include and try to work on with using DAX. It gives you a lot of freedom than the basic implicit functions that you already get from Power BI, like the aggregate functions like sum, average, mean, and median, right? Now let's consider a small use case for you. Now let's also find out, consider this as your homework. Now, just like we had the target for salespersons, let's have target for product as well. Or you can just simply write the DAX commands that you're going to perform on your Power BI in the comment section below. So write down a DAX function to find out the product's target. Let's say the minimum product sale, the minimum sales for a product is about 500, and find me out the products which achieved their target and which did not, so that we can find out the performance of product visually and identify which products needs a little bit of marketing and which are the products which are highly performing, and we can slightly increase the rates so that we can get a little bit of profit out of them. So this brings us to the end of module 7 on DAX basics. So let's continue with the next module where we will find out interactivity and drill downs, or basically creating a fully functional dashboard. So now we enter the next module where we will be understanding how to build charts and add slicers, filters, and basically create an interactive dashboard combining all the learnings that we have learned so far and create a completely business-oriented dashboard for interactivity and insights. So let's go with the Excel files for this particular data set. Now we have this particular Excel file here. Before we get started with the data set, let me bring back our learnings where I used to tell you once you use let's go back to Power Query once, where I said you there is this particular feature in Power Query where you just provide the location of the file once, right? Whether it is on a database or a server or a cloud, or if it is just a file location on your local system or anywhere, we just provide the location of the source and create some queries or create some steps for data cleaning. And after that, if you load the data to the platform like Power BI, the modeling or the data visualization becomes easier for you. And whenever you add new data to it, Power Query will automatically learn or use the learnings from the previous transformations and changes to the data set, and it will implement all those for you, makes the data clean, and you can just focus on data visualization without wasting any time on data cleaning or data transformation part. So we will be bringing that back in this particular demo. So here on my screen, you can see I'm providing a file name as location for our learning. So this location will have 1 year's data, which is very old, 2021's data. Let's assume that we have a business statement here, and we are comparing year on year performance wise. And here, if we come out of the location, here we have sales data for 2022, 25, 24, and so on, 23, right? They are ordered a little different, but not a problem. What majorly our concern is we are having 5 years of data, right? So we'll start our process of data visualization with one particular file, and then we will build an entire dashboard with just one file. And the magic happens at the last stage where we add all the new data, all this new data, what I'm talking about is, let me highlight them, all this new data into this file location. And once we add it, the dashboard, what happens in the background is Power Query will check all the data sets that we have recently added into the location, and it will reanalyze, rerun all the numbers and update the dashboard on the fly within a couple of seconds. So that's our approach. Now, the data that we are dealing with is here. This is the data set. We have sales data, so it is order ID, order date, on which date was the order placed, the delivery date, right? What was the delivery date, order status, if it is delivered or not. We have customer ID, we have customer name and last name, the state in which that particular product was delivered. We have the region, is it east or west, north, south, and central regions of the location, and what was the product, and what product or what category does the product belong to, if there is any subcategory for that as well, and the number of quantity, and what was the initial traffic to the website, and how many number of traffics converted into leads, and how many of those leads converted into orders, and what was the quantity, right? And we have cost to company and also revenue and profit. So profit is nothing but the difference between the cost to company and the revenue, right? You might create a product for 10 rupees and sell it for 12 rupees. Then your profit is 2 rupees. That's how revenue and profit and cost to company matter. So this is the overall basic agenda for our dataset. And this particular dataset is already cleaned. So we have split customer, first name, last name. And to reduce the length of this particular demo section, we have used the clean data, and you already have a good understanding of data cleaning, modeling, and DAX functionality so far. So we will be directly ingesting this data into Power BI platform. So I hope you have a good understanding of what kind of data set are we dealing with. We are dealing with sales data. We have order details, customer details, location details, and the traffic, lead, orders, revenue, profit, and quantity details in all in one shot. You don't have to, kind of create joins or merges. We also dealt with the joining data tables, merges, and how to append the data. And we don't have to work on all those complicated things. We can just understand basic functionality of how to create data visualization on Power BI platform, how to have a good background, a user interface. You'll also, so coming back to user interface, let me show you one of the interfaces that I created. So this particular image that you're seeing is created for user interface purpose only, user experience purpose only. So when you directly go into Power BI, you don't have such a beautiful, a good, decent, if not beautiful, a decent background. All you get is a plain white background, but it doesn't end there. Power BI gives you an opportunity to add or customize your own background to elevate the user experience for business leaders. So you need to understand what is the business purpose of your organization. So the purpose of this particular example is the business leaders wants to identify what is the traffic they are dealing with on monthly basis or year basis or provided date basis, and what are the leads. So here you can see we have state, year, and month. We can drill down. So we'll also go through drill down and drill through options. So we can drill down the sales date into years, into months, and dates as well. So here you can see month and year. So we can have that as well. So the business leaders wants to identify in a dedicated state, in a dedicated year, in a dedicated month, how was the traffic, how were the leads, how many number of orders did we receive, what was the revenue, and what is the quantity of orders did we receive. And if you scroll down a little bit, you can see region-wise sales, north region, south region, west region, east region, and central region, and category-wise sales. What category of products sold most in what region, segment-wise sales. So if you go through this, you can see how detailed this particular approach is. You can find a product level data, you can find subcategory level data, you can find category level data. Apart from this, you can also find out location wise data, which state had particular product sales high or low, which region of that particular state had a dedicated product high or low, right? And also you can see geographical location here, which is the biggest box. So in this biggest box, we will have one of the visualizations, which is geographical visualization, or also called as map chart. And here at the last, you have month-wise sales performance. So one thing to remember, whenever you're dealing with date-related data, if you have one of the measures or one of the dimensions as date, then it is by default, you should be going with a line graph, because line graph is the one which shows you the performance, if it is growing, if it is spiking, or if it is dipping, right? That's the purpose of using a line graph whenever you have date. So remember that. And rest of the ones, when it comes to the first row, state, year, and month, you can go ahead with filter or slicer. We'll also be customizing slicer. So the best part of this section is you can see the minute details, how, the slicer level things, the background for a slicer, the color for a slicer, the drop down choice, right? For a slicer, you'll be having a vertical box. You can customize that to a drop down. You can also ingest a feature where you can have a search bar logo on that, so that when you click on search, you can simply type which state you're looking for, and it pops out, filters out for you. And the same can be implemented for year and month. And you can also add KPIs, right? Cards are used for KPIs, key performance indicators, right? When to use cards, when to use a donut chart, when to use pie chart, when to use a bar graph, or when to use a column graph. Or apart from that, you'll also have a few more other alternatives like, a stacked bar graph, etc., and map chart. So you cannot use map chart for a bar graph, right? So the experience of using a dashboard matters a lot. So you can use, let's say, traffic by you can use a donut chart for indicating traffic. But will the purpose of indicating KPI be satisfied? No, right? So that's the basic sense you need to have. What kind of chart is created for what kind of indicator on a dashboard? When you're going ahead with KPIs, then cards are the best indicators. And when you're going with region-wise state, like when you have less than 5 dimensions or measures, it's better to go with the pie chart or a donut chart, because it gives you the accurate amount of division of sales between the regions. So in regions, we have about 5. So we have north, south, east, west, and central. So this type of chart or this type of measure can be depicted using a pie chart, which has better visuals. And same goes with category. We have a couple of categories like 5 to 6. Then you can go ahead with a donut chart and segment-wise sales as well, right? You need to have that simple understanding of what kind of chart is best suitable for what kind of representation of data. So this comes to the user experience and interface section. So you're free to use any tool for creating better backgrounds. I've used PowerPoint for creating this particular picture. You can use Canva or any online tools. You can also write a prompt to your ChatGPT and share the data with it, and share your business request or the business owner's requirements, so that it creates a good user experience or user visual for you, and you can download that and replace that with the background. So that's about it. So apart from this, we also have few other visuals. So here I have a social media dashboard. So you have follows, views, likes, shares, comments, right? If you're dealing with social media platforms, then you can go ahead with this one. So here we have buttons as well. X for Twitter, Meta for Facebook, Instagram, Snapchat, and YouTube. And you can also select the platform, state, region, resource. So we have this entire end-to-end tutorial on our channel. So you can also go through that. If you require this particularly, you can also comment us, and we'll share the dashboard with you and the tutorial with you. So we have a lot of different varieties of approaches for building a dashboard. So this was the one which we will be using today. So this is also one of the dashboards for creating sales one, and this is the one which we will be using today. So now with that, let's go to the Power BI platform. So let's give it a moment to load. So there you go. And we will be using a blank report for this one. Let's open a blank report. And to get data, we have a lot of options. Let me cancel this out. So to get data in the Power Query section, we have understood what are the different variety of sources available to get the data from. So here, I will not use Excel directly. What I'll do is I'll go to more options. And from here, I will have an option which says folder, right? When you select folder, it will ask you for the location of the folder, for the path of the folder, right? So you can open on browse window. Then your data is in downloads. My data is in downloads. You might have a different location as well. So here, or what I can do is I can cancel this. I can directly go to the window where I have my data. So it's easier for me to navigate. So it's in PBI and in location. So just copy this location. This is my location. Go back to Power BI platform and just paste the location over here and press OK. Now, what happens is Power BI will automatically understand which data is supposed to be loaded. So here I have the data set. Click on it. So there has been a small error. So let's try that once again. I think it took 2 sections or 2 rows. Must be a smaller, don't worry. Let's give it another try. Yeah. There is a small error here. Let's try that. Yeah, we need to drill down. Just click on that expand button and it will expand the data for you. And now select the sheet. This is the preview that we were looking for. And I think everything is good to go as this data was considered the best one. I mean, it was already cleaned. So let's anyways have a quick preview. So we have order ID, order date, delivery date, order status, customer ID, customer name, and state, region, product, category, subcategory, quantity, traffic, leads, orders, cost to company, revenue, and profit. So as we discussed during the tags module, unless you have a clean data fully functioning for analysis, you cannot proceed with analytics and it will not make any sense at the end of the dashboard. So I'm satisfied with my data. I want to click on OK for loading the data. So we have almost everything that we were looking for. So if we go back to data table view, I want to delete this particular one and go back to home. And I would quickly refresh the data. Now to the visualization train, and everything is now good to go. Now we will start with applying the canvas settings or canvas background. I would like to browse the picture that I created. So this was the one. Click open and image fit will be fit and transparency will be down so that we have a good visual. Discard the changes and we are almost good to go. Now that we have a good background, we will start with making the visualizations. So first we will come from top to bottom. So the top section is about including a state level slicer. So what I'll do is I'll go to the visualization screen. So here we have a wide variety of charts. We have stacked bar chart, we have stacked column chart, we have clustered bar chart, we have clustered column chart, and then we have a 100% stack chart. This is the column chart again. So this is the line graph which I was talking about. This is the area chart and the stacked area chart. Next is 100% stacked area. This is a combination of both column chart as well as a line chart, and there is a different purpose for this as well. So each and every chart available here has a different purpose. So this is the ribbon chart. This is one of the waterfall chart which we most commonly use, and then here we have a funnel chart, then the scatter chart. So scatter chart is really helpful when you have the comparison performance, right? So if you have, let's say, employees performing date to date, then you can go ahead with scatter plot. So it shows you an indication of growth as well as a performance on a dedicated spot. So the performance is spread in dots in the graph. Yeah, so you can go ahead with that. And the pie chart, donor charts that we discussed before. And we also have a tree map chart, which is similar to similar to pie chart and the donor chart. But the only difference is the representation will be in the form of blocks. And here we have the map chart, the geographical locations, and we have the filled map chart as well. So both stand same, but if you use map, the fill will be indicated in terms of a dot. But if you go to the filled map, you'll have fully filled geographical locations. And you have Azure map, you have a gauge here, and these are the cards. And next is multi-row card. Then this is the KPI indicator, the slicer, the regular table that we use, and this is the one, the matrix chart. We have R script visual, Python script visual, and we have key influencers and decomposition tree, Q&A questions as well. You can include this in the dashboard, and you can try to ask questions. Like, let's say I want to find out which product sold best in provided state in a provided year. Then you can quickly get that particular visual. This acts like a chatbot for your dashboard. That's a very good feature in Power BI. And then we have narrative, which explains or which gives out the narratives on the performance of dashboard. Then we have metrics preview, and we have paginated report, then the card and new slicers and all the other things, which is AGIS maps for Power BI, Power Apps for Power BI, and this is Power Automate for Power BI. So Power Automate is a whole new segment of learning. So we have a completely dedicated tutorial on Power Automate. So you can drop us a message in the comment section below so that we can share you the Power Automate tutorial for Power BI. So, and apart from that, if you see here, we have drill through and cross report options here. Now, let's get back to the dashboard and try to add the slices that we were discussing about. So we will just click on the slicer, and we have a slicer option right here. And let me drag and drop somewhere else. Now, here we will go into the visualizations format of this particular slicer. So let me drop the state location. So here we have now we have visuals. So we'll go into general, and I think we don't need a title for this one, so I'll keep it off. And we'll also go with the background. I don't want any background for this since we've already set it. And we don't want a visual border as well. And shadow, I think we don't need a shadow. Header icons, I don't need header icons. And background is also turned off. Transparency is 100% complete. Title is done. And properties. I think I'm almost satisfied with what I have. Now, apart from that, if we come into slicer visuals, I don't want the slicer header. And if we come into slicer settings, remember the drop down setting we spoke about? I don't want the vertical list. I want a quick drop down. So now I'll try to make it fit in the section where I,
created the state. So this would be it. So I'll try to rearrange it to fit into this particular space. There you go. Now what I can do is I can also include the search icon. So whenever I click on the drop down, I have a search bar over there. Let's say I want to find out maybe Madhya Pradesh. I can just type down Madhya Pradesh and I'll get it. So now that the slicer is fit and done, now what I can do is, to save time, I can just copy and paste it, right? I have a new slicer altogether. I'll just drag and drop this particular slicer to here, and similarly I will copy this again and paste. Now I'll drag and drop this to let me select it to month. So the only thing that we will be changing for this particular slicer is, so instead of state, we will be selecting year. So we have order date hierarchy here. So if you open the hierarchy, you can select year in place of state. So we'll unselect state. Now we here have all the years. So for now we just have 2021. So remember, we just selected one year per this particular visualization. So we will unselect state and we will open data hierarchy. So for date hierarchy, and then we will select month. So now we have all the states, all the years, just 2021 for now, but it will increase to 22, 3, 4, 5, and 6 later on. And we have all the months for the month section. Now the first slicer section is done. The next one is the cards. So what you can do is select a card, and this particular card will have the number of traffic. So you can see Power BI was able to calculate the summation, so it automatically aggregated the total traffic happened. So now we will go into visuals for this one. So general, and we want header icons. We don't want effects, so background will be turned off, and apart from that we don't want shadows and everything. So if you go into visuals, so here we will be having the category label. So we don't want category label because we already have a category labeled implemented into the dashboard itself. So we will drag and drop it somewhere here. And once you're happy with the location, the same thing what we did for slicer can be replicated here. So you can just copy and paste it. And now what you'll do is drag and drop to the leads section. You can also auto align that. And you can do the copy paste once again, and you can auto align to number of orders, copy and paste for revenue. So you can auto align for revenue as well. And one last copy paste for quantity. So copy and paste, auto align, and you have the quantity. Now what changes is, in leads, you need to unselect traffic and you need to select leads section. So here we have the summation of leads, and in the orders section, you need to unselect traffic and select the total automation, which is the aggregation for orders. Similarly, you can go to revenue, select the revenue summation and unselect traffic. And last is the quantity one. So you need to unselect traffic and go to total orders or total quantity of orders. So far so good. The first two rows are resolved. Now we have the region wise sales. Remember, we discussed if we have 4 to 5 elements and not more than that, you can definitely go with a pie chart. So we'll go with a pie chart here. Okay, let me quickly undo that. Okay, now select or click anywhere on the dashboard, and now click on the pie chart so that you have a fresh pie chart there. Now what you need to do is, we have legends, right? So I need to add region data into legend and values of orders to values. So there you go. Now you can go to the visualization. I don't want legend. I don't want you can have detailed labels, however,
And when it comes to title, I don't want title for this. I don't want header icons, and tooltips you can include, or if you don't want, you can also remove them. But I want detailed labels and any effects, visuals, background, and yeah, everything looks good to me. You don't have any background. Now you can slightly increase the size of the dashboard and make sure to fit it into the dedicated location provided for this particular visual. There you go. Now comes the category wise sale. So click anywhere on the dashboard, use a donut chart, and for this particular one, category. So where do we have the category? We have subcategory, and should be somewhere here. So we have the category here, and you can drop category to legends, and then you can order two values. There you have the category wise sales. Go to visuals, the same steps we did. We'll just have detailed labels, and title, we don't want the title, we don't want tooltips. Now you can close this, and just like we did for the previous one, you need to fit it into the space provided for this particular visualization. Now we have segment wise sales. So for segment wise sales, we have a lot of segments. So when you have a lot of segments, it's better you go with column charts. So I'll go with this particular column chart, and we have a column chart there. And now we will have segment in the X axis somewhere here. Look for segment. Okay, subcategory. I think subcategory, yeah, we do have a subcategory. I think we don't have a segment, but we do have a product. So I think it's better we go with product category wise, subcategory wise. So we have a lot of products, however. I think we missed out on the segment part. Or let's go to the table view quickly so that if we can find out we have any segments or not. This is the location, and here is the data customer. I think we don't have a segment, but that's okay, not a big deal. So in place of segment, we can include product, but we have a lot of products here. But anyways, in case if we apply a filter, let's say we apply a filter for a dedicated category, then we might drill down the products into a little bit. So let's have products there. Anyways, so drag and drop product to x-axis, and we will have orders in y-axis. It might be a little segregated, or it could be a little compact for this particular space. So we don't want header icons, don't want tooltips. We can keep tooltips, but for now it's okay. And yeah, everything is plot area background. So do we have a plot area background? No. So this is good to go. And same as before, we need to size this to the location provided. Yeah, similarly, we have a subcategory as well. So you can click anywhere on the dashboard and then go to visualizations. You can include a bar graph, and then what you can do is simply drag and drop subcategory to columns, and you can add orders, total orders to x-axis, and you'll identify how many number of orders were placed by how many number of products based on products. So you can click the visual, and just like we did before, we can make some general changes to it. We don't want title, we don't want header icons, and we don't want tooltips and visuals. So we don't want any plot area background. So far so good. So let's select all. Just like we did before, we need to fill in the area allocated for the subcategory. There you go. Now grid lines, we don't want grid lines. Size Just check for each and every aspect so that your slicer or your visual stands out, and ribbons, data labels, all the plot area. So the overall intention of creating a better visual experience for your end user is having a good representation of all the insights or visuals you build. So unless you take care of all these things, then you might end up in just another dashboard which doesn't look or feel good for the end user. So that now you have everything sorted out in one place. Now comes the next visual. So click anywhere on the dashboard, and then you need to click on the map, build map, or any map that you want, and then you need to open the data, and we will add state to the legend, and then what we will do is total orders, so that we will identify how many number of orders are being bought or are being received from entire location. So if you want roads, you can keep the roads. And general settings, we don't want title. We have already given the geographical location and tooltips. There you go. Now, or what you can do is you can quickly fill in this particular area dedicated for the map region. There you go. Now the last one is the sales month on month. Remember, whenever we are dealing with date to date, year to date, month to month, or last date today, remember the time functions that we discussed in time intelligence section. That's the one. So whenever you have time related data, repeat. So whenever you have time related data, go with line graph. So click anywhere on the dashboard, then go with a line graph, and your line graph will be created. Now on the x-axis, you need to drag and drop month. Inside the date hierarchy, you have month, right? So drag and drop that to x-axis so that you have month on month. And now drag and drop orders value to the y-axis so that you can see month on month performance. Similarly, go to the visual section, and here check all the aspects, and general section. And here we don't want title, header icons, and tooltips. So everything will be provided by just one click. So just close this one as well. Now extend this particular graph to fill in the area dedicated to that, and here you have the tooltips. So I think we need the tooltips. So go to the visualization section, and here go to So if you add tooltips, then you'll have the values which are happening in that particular location, right? So now you have a completely interactive dashboard. Now is the best part. So let's say I want to identify for a dedicated location, right? So here I will select Delhi, and I'll have the sales performance happening in Delhi right now. So we have about 17,000 traffic, and out of which we have 1800 leads, 19 orders, and so much revenue. So we need to expand this a little so that we have an actual number. So we have about 647 revenue, which can be in millions or something like that. And this is the total number of orders we receive, 207. And provided if you want to drill down a little bit, you can provide the dedicated month. So in the August month, so many leads were there, but no orders. So depends on the seasonal value also as well, right? So if you have April, then you might have okay, when you go into some other month, maybe June, so maybe some due to some seasonality, like any festive seasonality, you have some orders. So based on that, you can achieve some orders as well. So apart from that, so if you unselect Delhi, and you'll have the overall countrywide sales, revenue, orders, leads, and quantity details. Now comes the best part. Now let's go to the data location once again. So I have my data in KBI, and this is the location. Now what I'll do is select all these data sets, and what I'll do is simply drag and drop inside the location. I did not do anything yet. Now I'll close this and go to the dashboard. Nothing changed as of now. What I simply do is refresh the data. Once I click on the refresh data, new data is being loaded. Just click on close. Now you have the data for all the years. So if I click on year, so you can see automatically we have 2021, 22, 23, 24, and 25. Initially, we just had 1 year, which was 2021. So all the data cleaning that we did, like a quick review of what the data is looking like or what columns and rows we have, right? All that part has been done automatically or implicitly inside Power Query, and we have all the data ready for publishing or sharing with our business owners or your clients, basically. So now the next point is all about publishing this particular report or sharing this particular link to the business owner. And in the next section, we will be learning this. And that brings us to the end of this particular module on data visualization, charts, and adding interactivity, drill down, and all the aspects of a data analysis dashboard using Power BI. Welcome to module number 9. In this session, we will move beyond Power BI Desktop and into the Power BI Service, the cloud platform where you publish, manage, refresh, share, and embed reports at a scale. By the end of this module, you will be able to publish a .pbix file from Power BI Desktop to the Power BI Service and understand what is being published, which are reports, dataset, or model, etc. You can manage workspaces, roles, and the lifecycle of content and datasets. Configure dataset, which is refresh, including gateways, credentials, incremental refresh, and troubleshooting. You can also share reports and dashboards with users and teams effectively while maintaining security and governance. You can also embed reports into applications and web portals and understand the difference between embedded models and permissioning approaches. We will balance step by step, which is how to instructions with architectural reasons and governance best practices. So you know both what to click and why that choice matters in real business. So let's get started with part A of module 9. So the part A will be basically about how publishing works. So you need to navigate to desktop, then choose the service option. So let's start publishing. Publishing is the act of taking Power BI file, which is .pbix file you built in Power BI Desktop, and uploading it into the Power BI service, which is app.powerbi.com, where it becomes a dataset, a report, and optionally a data flow or paginated report, depending upon how you build it and what you build, what you publish, when you publish from desktop, and how effectively you upload the three things: the report definition, the collection of page visuals, bookmarks, and layout; the dataset or semantic model, which is the second one, which is about the tables, relationships, DAX measures, metadata, and the connection strategy, which is basically how to import data query or a live connection. Then comes any query logic, the Power Query steps that you made, the produced data, the service stores, and the query logic in the dataset, so future refreshers can rerun the extract or transform steps carefully. Put simply, the report is the front end, the dataset is the engine, and the query logic is the recipe that builds the engine from source systems. How to publish step by step. So from Power BI Desktop, you can either select the file to publish the Power BI option, or directly you can choose to click on the publish button from the home ribbon. You'll be asked to pick a workspace destination. Select the workspace you own or have publish permissions to. The desktop app then uploads the .pbix file to the selected workspace. After a successful publish, you can open the report in the Power BI service and the dataset will appear under the workspace dataset section. Now, let's go through the key considerations when publishing. So firstly, the workspace choice matters. Don't publish into My Workspace, which is the default location for production reports. Use dedicated workspaces that you create for your teams, projects, or production apps. Workspaces map to content lifecycle and permission boundaries. A workspace should be the unit of collaboration and governance. We will dive into workspace roles shortly. So connection mode influences refresh and performance. If your dataset uses import mode, then Power BI stores a copy of the data and you must schedule refreshes. If it uses direct query or a live connection, the service queries at the source at runtime or caches limited resources or results, changing how refreshes handle and affecting concurrency and latency. So for this reason, it is better that you always choose the mode that matches your SLA and data size. Next is size limits and licensing. Large datasets and high refresh frequency may require premium or PPU capabilities. Check the organization's license and workspace capacity. If you run into file size limits, consider optimizing the model, where you can remove unused columns or use aggregations or move to a premium capacity. What to expect after publishing? Once published, your colleagues can view the report in the workspace if they have access, provided if they have access to it. The dataset can be refreshed on schedule, and you can package the workspace content into an app to distribute to a larger audience. You can also download the report back as .pbix if permissions allow you. The service stores publication history and basic lineage. That's the publishing core. Next, we will look into workspace architecture and how to manage datasets after they are in the service. So let's go into the part B, which deals with workspace management. So roles, apps, and the best practices. Workspaces are the organized container in Power BI service. They hold reports, dashboards, datasets, data flows, and paginated reports. Workspaces are where teams collaborate, prepare apps, and manage lifecycle between development, test, and production. Now let's also take a look through types of workspaces. Microsoft has new modern workspaces which replace classic work pages. They provide better role control, governance features, and app publishing options. They create a workspace for each logical area or project rather than using a single workspace for everything. Now let's go with roles within a workspace. There are distinct roles you can assign to people and security groups. For example, we have admin. So admin has full control. He can manage workspace settings. He can add or remove members and delete workspaces as well. Then comes the member, who has the permissions to edit content, publish reports, and create apps. Followed by that, we have contributor, who has the right to publish and update the content, but has limited management rights. Then we have the viewer, who has only read-only access to the content inside the workspace. They can't edit or do anything with the report. Now, assign the least privileged role necessary. For production workspaces, used to publish apps, keep these sets of admins small, and use members or contributors for content authors. Viewer role is ideal for users who only need to consume reports without editing. Now, let's discuss the difference between apps versus the direct workspace consumption. An app is a packaged, curated distribution of selected workspace content intended for broader audience. It provides a stable URL, consistent navigation, and controlled access. Use apps when you want to distribute read-only content to a larger user base. Use workspace access when the audience needs collaborative editing or testing. Now let's discuss about the workspace lifecycle and governance best practices. So it comes from developer to QA, QA to production. Maintain separate workspaces for development, testing, and production. You need to encourage authors to publish to dev, QA, or validation, and then promote the production, where you can republish or deploy the apps. Now let's go through the naming conventions. Name workspaces and datasets clearly. Include environment tag. For example, sales production, sales development, right? These are the tags you can use. And next comes the content endorsement. Use endorsement, for example, certified or promoted for trusted datasets to guide users to its single resources of truth. Certified datasets indicate governance vetting. Now let's go through metadata and documentation. Add descriptions to datasets and reports and keep a README page in Workspace with intended use. Data sources and owners contact as well. This will be helpful. Now let's go through monitor lineage and usage. Use Workspace and tenant usage metrics to track adoption and performance. Remove stale content and archive older versions. So let's go through an example. Imagine a company BI team supports sales reporting. You need to create 3 workspaces. First one, which is sales developer, which has only authors who build the reports. Next is sales QA, which has analysts to validate the report. And lastly, we have sales app, which is production app published to all sales managers in one go. Now, Only a small set of admins and members exist in developer or QA teams. While the app is distributed to hundreds of viewers, proper workspace management reduces confusion, enforces governance, and controls cost, which is capacity of usage. Now, let's dive into the part C, data refresh. The concept, setup, and troubleshooting will be dealt here. One of the most important operations after publishing is keeping your dataset current. Dataset refresh is how Power BI updates the imported data in the cloud so reports show recent information. So now let's discuss the refresh modes and triggers. There are multiple refresh mechanisms. So the first one is scheduled refresh. The most common one is this one. You can configure frequency in the dataset settings, which is based on hourly, daily, or even weekly. Power BI will run the stored Power Query steps and reload data from import mode datasets. Next is on-demand or manual refresh. You can run a refresh immediately after the dataset UI. Useful for ad hoc updates. Now let's go through push and streaming datasets. It is used in real-time scenarios where external services push the data into the Power BI. Followed by that, we have Power Automate or API. So this is actually a trigger refresh which happens through automation flows or API calls for event-based updates. This is useful when data source systems signal the data changes. Now comes the gateways and on-premise data. If your data source are on-premise like SQL Server, analysis services, files on network share, etc., you need an on-premise data gateway, which is a lightweight service that securely facilitates connections between Power BI in the cloud and your internal data. Install the gateway on a reliable server, register it to your tenant, and assign it to the workspace or the dataset. The gateway supports clustered mode for high availability. Don't run the gateway on a laptop. Use a server class machine and put it behind appropriate monitoring. Next, let's discuss about the credentials and privacy levels. In the dataset settings, you will set the data source credentials. Make sure credentials are valid and use service accounts when possible rather than personal accounts. Review privacy levels if used for proper data handling of joint data. When credentials fail, your refreshes will error out. The refresh history gives you the failure message to diagnose. Now let's move into incremental refresh to scale large datasets. For large tables, use incremental refresh to avoid reloading entire tables every time. Incremental refresh allows you to partition time-based data, refreshing only recent partitions and keeping historical partitions static. A huge performance win. To use it, you typically define range start and range end parameters in Power Query and enable incremental policies on the dataset in the service. This feature is essential on large datasets and often paired with premium or PPU capabilities for higher limits. Now let's discuss the refresh limits and quotas. Be aware of refresh limits related to license type. Free workspaces have limited refresh options. Pro and PPU have larger quotas, and Premium provides the most frequent and larger model support. If you need many hourly refreshes across many datasets, Premium capacity is usually required. Now, let's go through troubleshooting refresh failures, which is a practical flow. So, check refresh history. The dataset settings page contains the refresh history and no error messages. Note timestamps, error types, and affected tables. Next, we have verify credentials. Test data source connections in dataset settings, update passwords or service account tokens as needed. Then we have gateway status. Confirm the gateway is online and on the latest version. If the gateway is offline, refreshes will fail. Check gateway logs and network connectivity. Timeout and query issues. If refreshes timeout, look at query complexity, break down running transformations, or push transformations to the source. Consider aggregations or move heavy transformations upstream. Next ahead, we have concurrency and capacity. If many datasets refresh simultaneously, the queue can delay refreshes, stagger refresh schedules, or scale capacity. Use the Premium Capacity Metrics app to monitor the saturation. Followed by that, we have data schema changes. If the source changes column names or data types, Power Query steps can break. Maintain communication channels with data owners before source updates. Now let's go to some advanced options. Refresh templates and cascading refresh, which is from Fabric. So for complex pipelines with semantic models and data pipelines, you can orchestrate refresh templates or chain refreshes so upstream data flows refresh before downstream data sets. This gives more reliable end-to-end data refresh in advanced architectures. Now let's go through an example scenario. Let's imagine a retail company imports daily sales. They use the incremental refresh policy to update only the last 14 days each night and a smaller hourly refresh during business hours for the previous day's rolling window. The gateway connects to their on-premise POS database and the admin monitors refresh failures via the refresh history and capacity metrics. The design reduces load, improves freshness, and keeps costs predictable. Now let's dive into the part D, which is about sharing reports and dashboards with teams and people. So publishing is one thing, sharing is where insights drive action. Power BI provides multiple sharing patterns. Choose the pattern that matches your audience, governance, and licensing. Now let's go through the sharing options overview. Workspace access. You can grant user roles inside a workspace based on viewer, contributor, or member, or even admin. Use this for collaboration where users may edit or test the content. Next is publish an app. Best for distributing polished, read-only content to many users in one go. Apps are versioned and provide a stable entry point for consumers. Next is the share option. The share button lets you send a direct link to the specific people or groups. This respects dataset RLS and requires recipients to have appropriate license or access. Use this for ad hoc distribution. Followed by that, we have embed in Teams. Add reports as tabs inside Teams, channels, or chats so users access analytics where they work. Embedding in Teams keeps collaboration seamless and can include comment and chat integrations. Next, we have secured embed or public embed or publish to web options. Secure embed option is for internal portals with authentication. Publish to web produces an anonymous public link. Use with extreme caution. It is used rarely for internal data only. Secure embed respects permissions with row-level security. Public embed is not. Now, let's dive into embedding in Microsoft Teams. So let's go through the practical flow. To add a report to a team channel, open the channel, click the plus icon, select the Power BI tab, then pick the Power BI report or dashboard you want to embed. The Teams tab gives users direct access to the report without leaving Teams, and you can pin it for quick visibility. This is a strong pattern for operational teams that already use Teams for daily communications. Next comes the row-level security and sharing. When sharing, ensure RLS is configured if recipient should only view a subset of the data. RLS is defined on the dataset and enforced by the service. It travels with the dataset and applies to all sharing mechanisms, including apps and team tabs. Use RLS carefully and test via view as a role to confirm behavior before wide distribution. Now, let's go through external sharing and B2B. You can share with external users via Azure AD B2B. Tenant admin must enable external guest settings. For customer-facing scenarios, consider Power BI Embedded, which is app owns data, to avoid provisioning licenses for external users. Always follow your organization's tenant settings policies and consult compliance teams for external data sharing. Now, let's go through best practices when sharing. Use apps for broad audiences, package reports and dashboards into apps with controlled permissions, and publish app updates rather than republishing workspace content. Next is document expectations. Every app report should include data refresh schedule, owner contacts, and intended use. Protect sensitive data. Use sensitivity labels and tenant settings to restrict export printing or sharing where needed. Training and adoption is the next step. Create short walkthroughs inside Teams or pin documents so business users know how to navigate reports and filter correctly. Next comes an example. The HR analytics team publishes a headcount and attrition app. They deploy it to the HR app workspace, run RLS so managers see only their teams, and add the app as a tab in each manager's team channel with a pinned frequently asked questions tab. Managers receive an email when the app updates, and the HR team monitors usage metrics to iterate. Now, let's dive into the part E, where we will discuss about embedding reports, approaches, authentication, and permissions. Now let's go into part E, where we have embedding reports, approaches, authentication, and permissions. Embedding is where Power BI becomes a part of product experience and workflows. There are two main embedding models, and each has different security and licensing implications. Embedding for your organization where users own the data. This is internal embedding where the end user needs to authenticate with their Power BI credentials. The report respects their permissions and row-level security. Now let's go through some use cases. Intranet portals and internal web apps where only authenticated employees access the analytics. Authentication typically uses OAuth with delegated permissions only. Now let's go for another one, which is embed for your customers, where the app owns the data. This is an external model where the application authenticates using a service principal or master account and renders reports to the end users who don't have Power BI accounts. This is the recommended approach for ISVs and SaaS apps. It requires Azure setup, which is Power BI embedded capacity, and careful security design. Use the REST APIs with a service principal to acquire embedded tokens for the client app. Next comes authentication options for embedding. User authentication, which is delegated. Users sign in with Azure AD. The embed respects their direct permissions. Use this when users already have Power BI licenses. Next is service principal, where we have only the app. It is recommended for app owns data scenarios. You can create an Entra app, grant Power BI API permissions, and use the client ID plus secret to authenticate server to server. Generate embed tokens with the REST API and pass them to the front end. This approach lets you control which reports a user can see without giving them the Power BI account. Now let's go through embedding methods and security trade-offs. So the first one, secure embed code or iframe. It is good for internal portals. It respects Power BI permission, but still requires users to sign in. It's the simplest path when you have basic embedding needs and internal authentication.
Now, the next one is Power BI Embedded, which is dealing with Azure. It provides an Azure-based hosting capacity for external embedding with higher scale and performance guarantees. You manage capacity, scale units, and the cost at Azure level. This is the correct choice for commercial products. Now let's go through Publish to Web. This one creates a public anonymous embedded URL. You need to avoid this for internal or sensitive data. It is effectively public. Use only for fully public or non-sensitive visuals. Next is about permissions and row-level security in embedding. When using user owns data, RLS continues to work as usual. Each user sees the data according to their role. When app owns data, you often need to implement row-level filters at the embed token generation step to ensure each customer or tenant sees only their data. Use the REST API's embedded token generation and specify effective identities or RLS filters to restrict data. Test extensively. Now, let's go through practical architecture for ISV where app owns the data. Provision Power BI embedded capacity in Azure. Create a service principal in Microsoft Entra and grant it to the required Power BI API permissions. Use your backend server to call the Power BI REST API to authenticate, create or refresh datasets as needed, and generate embed tokens. Securely hand the embed token to the client browser for rendering via Power BI JavaScript software development kit. Rotate secrets and monitor usage and errors. Embedding example, secure internal portal. A company builds an internal vendor portal where each vendor can log in and view their performance dashboards. They choose secure embed with user authentication. Vendors authenticate via SSO and the portal uses an iframe or direct embed to render Power BI reports. RLS ensures each vendor sees only their data. The portal does not store embed tokens for long term. Now let's go through developer and security checklist for embedding. Use TLS and secure cookies. Rotate service principal secrets for every 90 days or use certificates. Log all token requests and embed activity for audit. Use throttling, retry patterns, and circuit breakers for REST API calls. Monitor capacity usage to prevent throttling or excessive cost. Embedding turns analytics into part of workflows and products. Choosing the right embedding model is a balance between user experience, cost, and security. And with that, we dive into part F, which is about permissions, governance, and tenant settings. Security and governance are the core. Power BI tenant settings and workspace rules provide guardrails. Tenant level governance. Administrators can set tenant wide policies such as allowing or blocking external sharing, enabling or disabling publish to web, managing who can create workspaces or use premium features, controlling which users can export data or reshare data reports, controlling which users can export data or reshare the reports. Work with the Office 365, Entra AD, and Power BI admin teams to create sensible defaults that align with corporate policy. Data sensitivity and protection is our next point. You can use Microsoft Purview sensitivity labels if available to tag datasets and reports. Labels travel with content and control export, print, or copy behavior. Pair sensitivity labels with tenant export controls to limit data exfiltration. For regulated data, consult data protection officers and legal counsel. Now, let's go through permission best practices. Let's start with least privilege. Only give the permissions that users need. Group-based access is the next one. Use Azure AD groups to manage workspace membership rather than assigning permissions to individuals. Next is service accounts. Use dedicated service accounts for schedule refreshes and APIs, not personal accounts. After that, we have audit and monitoring. Enable audit logs and review sharing patterns. Watch for unusual exports or public links. Now, let's discuss governance example. Finance publishes financial dashboard but restricts export and sharing. The tenant disables publish to web globally, and the finance workspace requires two admins and enforces certified datasets only. This ensures sensitive financial data is controlled and traceable. Now, let's have a quick closing summary and practical action plan. Let's summarize the core takeaways. Publishing moves your .bbix into Power BI service as a report, dataset, and query recipe. Choose the right workspace and connection mode before publishing. Workspaces are the primary collaboration and governance container. So use roles and developer to quality analyst to production patterns to manage content lifecycle. Dataset refreshes is critical for data freshness. Use gateways for on-premise resources, incremental refresh for large tables, and monitor refresh history for failures. Sharing should be intentional. Apps for broad audiences, workspace access for collaborators and team, embedding for everyday workflows, respect RLS and security. Embedding has two main models: user owns data, which is internal, and app owns data, which is external. Choose according to the licensing and business needs and secure via service principals and embed tokens for app owns data scenarios. So now let's discuss an action plan for learners. Publish a sample.bbix to a developer workspace, inspect the dataset, refresh it manually, and configure scheduled refresh options. Create a small workspace with member and viewer roles, publish an app, and install the app as an user. Now you can add a Power BI tab to the Teams channel and embed the report. Test the filter, add comments. If you have a developer background, you can generate an embed token using a service principal for test app. Work with your tenant admin to understand your organization's tenant settings and refresh quotas. Recommended reading and resources: publishing and uploading Microsoft Docs, Workspace and role guidance, Power BI docs on new workspaces, schedule and manage dataset refresh, Power BI refresh docs, embed in Teams documentation and embedding Power BI and Microsoft Teams, embedding APS and service principal guidance, Power BI REST API docs. That wraps Module 9. In the next module, we will cover report optimization, large model strategy, and best practices for performance tuning in Power BI. Now we enter Module 9, which is about Power BI tips, tricks, and common mistakes. So, in this module, we are moving beyond the basics and intermediate skills. We are focusing on the advanced habits that make Power BI users truly efficient, reliable, and professional. If you think of everything we have covered so far: data loading, Power Query transformations, modeling, DAGs, visualizations, and publishing, these are the building blocks. Module 10 is where we refine these blocks into a professional analytics system that is fast, scalable, consistent, accurate, easy to maintain, easy to understand. This module is important because most Power BI performance problems, business confusion, or dashboard failures don't come from Power BI itself. They come from avoidable mistakes such as poor modeling, incorrect tags, unnecessary visuals, or inefficient refresh processes. So, in today's session, we will go deep into performance optimization tips, avoiding common tax pitfalls, best practices for dashboard design, using Q&A visuals, and smart narratives for storytelling. By the end, you will have a complete mental toolkit that will help you build dashboards like an enterprise level BI engineer, not just a casual report creator. So let's begin. The first section will be about performance optimization tips. Performance optimization is one of the most underrated skills in Power BI. Many users think performance issues only come from large datasets, but that's not entirely true. A poorly designed model with even moderate data can cause slow refresh, visual loading delays, memory overflows, frozen interactions, slow DAX measures, and many more. So, let's go step by step through the most important optimization techniques. So, the first one, reduce the model size. A lighter model loads faster, refreshes faster, and easier to maintain. So, here comes the tip one, remove unnecessary columns. Many datasets come with 100 plus columns, but typically only 20 to 30 are actually needed for reporting. So if you want to go through some examples of columns that you can remove, so some of the columns that you can remove are the columns which are only used for intermediate calculations. Audit fields like created by, updated by, columns with extremely high cardinality where you only need aggregates, pre-text comments, descriptions, or log columns that duplicate information like multiple versions of dates. Every unnecessary column increases refresh time. Removing even 10 such unused columns can significantly reduce model weight. Now, the next step, reduce data cardinality. Cardinality means the number of unique values in a column. High cardinality is equal to slow performance. For example, a column with 1 million unique customer IDs, a date time column with timestamps for every second, a text field where every value is unique. All this creates pressure on Vertipack engine. Now, let's go through the optimization techniques. You can convert the date time data type, date of minutes, seconds that are not needed. Reduce precision of numerical values. Group or bin data where possible. For example, if you have multiple ages, then you can segregate them into a group from minimum age, that is 18 to 30, 30 to 60, and beyond. So you have three groups here. Avoid using GUIDs in visuals. Avoid using unique IDs in slices. Reducing cardinality improves compression and speeds up calculations. Now the third tip, disable auto date time. Power BI has a feature called auto date time, which automatically generates hidden date tables. For small projects, it's fine, but professional BI models, it should always be turned off. Why, you ask? Because it silently adds extra tables, which increases model size, relationship overhead, memory usage. Instead, always create your own date table marked as date table. Now, the fourth tip, use star schema for better performance. The most powerful optimization is correct modeling. A star schema ensures cleaner relationships, faster DAX evaluation, smaller models, predictable performance, and a lot more. In star schema, fact tables store numeric transactional data. Dimension tables store categories like product, region, or customer data. Many performance issues occur because users build flat tables or snowflake models with long chain. So, you need to consider one rule of thumb. One fact table connected to multiple dimensions is always faster than multiple flat tables. Now, the fifth tip, limit the number of visuals per page. Every visual is a query. Having too many visuals slows page Having too many visuals slows page load, increases memory usage, reduces responsiveness, increases dataset refresh time for direct query models. Recommended limits. Standard reports 6 to 12 visuals per page, executive dashboards 4 to 8 visuals, highly interactive pages 1 to 3 visuals plus slicers. If you need more, create drill down or drill through pages, bookmarks, or tooltips instead. Now, the sixth tip, avoid using too many slicers. Slicers may look simple, but they're expensive. Each slicer refreshes the entire page every time the selection changes. Replace slicers with drop downs, filter panes, drill through, filter report level, filters, buttons, or bookmark navigations. Only use slicers when user genuinely needs to make frequent selections. Now we have the tip number 7. Use measure tables. Professional Power BI reports separate measures from data tables. A measure table organizes calculations, improves model clarity, reduces accidental misuse of columns, enhances DAX performance because measures are calculated on demand. Never store measures inside fact tables. Now we have our next tip, which is about optimizing DAX. We will cover DAX mistakes in the next section, but performance optimization is deeply tied to DAX efficiency. A poorly written DAX formula can slow the entire model. For example, using SumX on large tables when sum is enough. Second example is using calculate unnecessarily. After that, we have using filter on entire tables instead of just few columns. Overusing all except, and remove filters is also one of the good examples. Great performance comes from minimal efficient formulas. Now the ninth tip. Avoid using many calculated columns. Calculated columns increase the model size and these are computed at refresh time and are often found to be slow. These are usually replaceable by measures. You can reduce performance for composite models as well. Only choose to use the calculated columns if the logic cannot be handled by measures or a simple Power Query. 90% of calculated columns actually belong to the Power Query, not DAX. Now the 10th tip, use aggregation tables for large models. For very large datasets, millions to billions of rows, Power BI supports aggregation tables. Aggregated tables pre-calculate high-level summaries, reduce calculations, improve direct query performance, make dashboards more responsive. This is commonly used in finance, manufacturing, and IoT analytics. Now let's have a short recap of the section 1. In summary, performance optimization is not one thing. It's a combination of disciplined habits. Following these practices ensures smooth dashboards, reliable refresh cycles, and scalable models. Now, let's go to the section 2 of module 10, which is about avoiding common DAX pitfalls. This is one of the most important parts of today's module. Knowing DAX is one thing. Knowing how to avoid DAX mistakes is what makes you a true BI professional. So, the DAX issues almost always lead to incorrect numbers, confusing visuals, wrong totals, slow performance, incorrect filters, and a lot more. So, let's walk through the biggest pitfalls and how to avoid them. Now, the first one is misunderstanding row context versus filter context. This is the number one mistakes new users always make. Row context applies to each row in a table. Filter context, on the other hand, comes from slicers, filters, or calculate options. You must always remember a calculated column has row context, a measure does not. This is why formulas behave differently. Now let's go through some examples. Sum of sales of revenue. In a calculated column, this gives the same value on every row. In a measure, it changes based on visuals and filters. Misunderstanding this creates endless confusion. Now the second one, overusing calculated columns instead of measures. Many beginners use calculated columns for everything because they behave more like Excel formulas. This leads to bloated models, slow refresh rates, memory inefficiency, incorrect aggregations, and a lot more. Always ask, can this be done with a measure? If yes, then always prefer a measure. Now, let's go to the third one, using calculate even when not needed. Calculate is powerful, but many people use it unnecessarily. For example, calculate sum of sales of revenue. This is pointless because sum already respects filter context. Only use calculate when you want to change the filter context. Followed by that, we have using filter on the entire table. Example, let's consider a mistake where you added calculate function of sum of sales revenue and then you added a filter for sales region, which is equals to east. Instead of using this, you can simply write calculation method inside sum of sales revenue and sales region is equals to east. Now this filter adds row context, slow, and column filters are faster. Now let's go through the fifth one, misusing all method. removing filters, and all except. These functions remove filters, but many users apply them blindly. Now let's consider an example mistake. So here total revenue is equals to calculate sum of sales revenue and all sales. This removes all filters, even date filters. This particular approach removes all filters, even date filters. Always think which filters should remain, which filters should reset. If you want only a specific filter to be removed, be precise. For example, all sales of region, not the whole table. Now, let's go through the sixth mistake. Improper time intelligence calculations. Tax time intelligence requires a continuous date table, no gaps, a mark date table. If your date table is incorrect, functions like same period last year, total year to year, which is total YTD for short, date add, these functions will return incorrect values. Now let's go through the seventh mistake. Using earlier instead of variables. Earlier is an outdated and confusing function. Instead, use variables. An example is VAR current value equals to sales revenue, return current value, previous value, etc. Variables improve readability, improve performance, prevent repeated calculations, reduce mistakes, and a lot more. Now let's go through the eighth one, not using divide function. Divide handles division by 0 gracefully. Now let's consider a bad usage. For example, sales of revenue divided by sales of quantity. So for a better approach, you can use divide method, sales of revenue, comma, sales of quantity, comma, 0. Always use divide method to avoid errors. Now let's go through the ninth one, ignoring DAX query plans. Power BI has tools like DAX Studio, Vertipack Analyzer, Performance Analyzer, and a lot more. These reveal expensive measures, slow queries, heavy tables, and a lot more. Professional BI engineers always test performance before deploying large-scale dashboards. Now, let's have a quick recap of the section 2. DAX mistakes usually come from misunderstanding context. Once you master context, your formulas become faster, cleaner, and more reliable. Now, let's dive into the section 3, which is about best practices for dashboard design. In this section, we will shift from performance to design, the user experience portion of the Power BI. A dashboard is only as good as its design. Users should be able to look at your dashboard and instantly understand. The user should be able to understand what's the story, the trend, the insights, the action plan, and a lot more just by looking at your data dashboard. Now, let's look at some of the best practices that professional always follows. Now, the first one, apply the 5-second rule. A well-designed dashboard should make sense within 5 seconds. If the user needs to scroll, zoom, decode, guess, or mentally calculate, then the dashboard has already failed. Dashboards must deliver insights quickly and cleanly. Now, the second one is avoid chart overload. Not all charts are equal. Avoid some charts, for example, 3D charts, donut charts with more than 4 circles, pie charts comparing similar values, clustered bar charts with too many categories, maps with too many points, etc. Instead, you can prefer bar charts, line charts, matrices KPI cards, scatter plots for correlation, decomposition tree for root cause analysis, waterfall for financial analysis, and similarly, we have other options as well. Simplicity always wins. Now, let's go with the third one, maintain visual hierarchy. Visual hierarchy means guiding the viewer's eyes. Use large fonts for key KPIs, bold colors for important numbers, consistent placements, white spaces, grouping and alignment, and these things are to be considered. Use large fonts for key KPIs, bold colors for important numbers, consistent placement, white space, grouping, and alignment. A clean dashboard reduces cognitive load. Now, the fourth one, use consistent formatting. Consistency builds trust. Use the same number formats, colors, decimal points or decimal places, date formats, naming conventions, and etc. For example, if revenue is in millions, keep it in millions everywhere. Now, the fifth point, keep colors meaningful. Avoid random colors. Use consistent meanings. Let's consider green for good, red for bad, blue for neutral, and yellow for a warning. Avoid too many colors. Try to keep it within a limit of 3 to 5. Now, let's go with the sixth point. Use tooltips for depth, not overcrowding. Tooltips help keep dashboards clean. Instead of adding extra visuals, add details to tooltips. Use report page tooltips. Provide drill through options. This keeps the main dashboard. Provide drill through options. This keeps the main dashboard minimal but yet powerful. Now comes the seventh point. Use bookmarks for navigation. Bookmarks can create guided stories, step by step narratives, collapsible filter panels, interactive instructions, and a lot more. Bookmarks often elevate dashboards into apps. Now, the eighth one, hide the complexity from the user. Always design dashboards so that actions are intuitive, slices are minimal, visuals are self explanatory, navigation is almost effortless. The goal is to deliver insights, not complexity. Now we dive into the section 4, which is about Q&As, visuals, and smart narratives. This section focuses on Power BI's AI-driven storytelling. This section focuses on Power BI's AI-driven storytelling tools. These tools help users ask questions and generate insights automatically. Now the first one, Q&A visual. The Q&A visual allows users to type natural language questions like what are the total sales by region in 2024, what are the top 10 products by profit, monthly revenue trend for a specified country, etc. Now, Power BI interprets these questions and generates the chart automatically. Now let's go through the best practices. Use proper field names, create synonyms, build a glossary, train the Q&A engine, and use the suggested questions only. This makes dashboards conversational. Now, let's move into the second one, which is about smart narratives. Smart narratives automatically summarize the trends, outliners, key insights, differences, and anomalies. It generates text that explains what the charts show. For example, revenue is increased by 12% in Q4 and it is driven by strong performance in the electronics segment. This adds storytelling to dashboards. Now let's go to the third point, narrative customization. You can customize smart narratives by adding your own text, highlighting key metrics, creating dynamic summaries, linking measures. This ensures that executives can read insights in plain language. Now, let's go to the next one, which is storytelling with Power BI. A great dashboard isn't just a collection of visuals, it tells a story. A story should answer what happened, why did it happen, why is it important, what should you do next. Smart narratives plus Q&A plus bookmarks plus drill through create powerful storytelling experiences. Now, the conclusion to this particular module. Module 10 wraps up all the advanced principles needed to build enterprise level Power BI dashboards. We covered optimization techniques for high performance, DAX mistakes and how to avoid them, best design practices, AI driven storytelling, and a lot more. These skills will significantly improve the speed, clarity, and impact of your dashboard. In the next module, we will conclude the course with advanced deployment and governance best practices. So, welcome to the final module of this Power BI full course for beginners. In this chapter, we are going to do three major things. Recap everything you have learned across the 11 chapter journey, provide most reliable resources for going advanced, and third one, give you a complete roadmap to crack the PL300 Power BI Data Analyst certification. So by the end of this module, you'll have clarity on how data flows through Power BI, how each module contributed to building your Power BI skill set, what you should practice for next, and exactly how to prepare for the industry recognized certification. So let's begin with the detailed recap. Chapter-wise summary recap starts now. Chapter 1 recap, Introduction to Power BI. In this chapter, we laid the foundation for your entire Power BI journey. We started by understanding what Power BI actually is, not just as a tool, but as a complete ecosystem for business intelligence. We discussed the importance in 2026 and beyond, especially as companies shift from manual reporting to automated data-driven cultures. You learned that Power BI is composed of Power BI Desktop, where you build reports, and Power BI Service, where you publish and share the reports, Power BI Mobile, where the leaders consume the insights on the go. You also explored the real world use cases of Power BI, marketing team analyzing campaign performance, sales teams forecasting revenue pipelines, finance teams automating MIS and dashboards, HR teams monitoring employee performance and hiring metrics, operation teams optimizing supply chains and logistics. Finally, you installed and set up Power BI Desktop, preparing your environment for rest of the course. Now we dive into the chapter 2 recap. You have understood Power BI workflow here. This chapter explains Power BI's end-to-end workflow, which mirrors how organizations actually use the BI. It all starts from data, next to transform, next to model, then visualize, then publish and share, and lastly automate. We broke down each layer. Data sources like Excel, CSV, SQL Server, cloud services, transformations using Power Query, where we did the cleaning operations, modeling, where we established relationships using star schema, visualizations, where we created interactive and insightful charts. Then comes the publishing, where we uploaded the dashboard to Power BI service, sharing and governance using workspaces, permission, and apps. By understanding this workflow early on, you were better prepared for the practical steps that followed. Now we dive into the chapter 3's recap, which is about connecting to data sources. Chapter 3 was your introduction to real data ingestion. You learned how to import Excel and CSV files, pull data from the web, connect live to SQL Server, understand the difference between import mode and direct query, understand dual mode and when to use each. We discussed real life scenarios like import mode for faster dashboards, direct query for real time analytics, live connections for enterprise semantic models, etc. We also learned how businesses often deal with multiple systems, ERPs, CRMs, marketing systems, and how Power BI acts as a central reporting layer. Now, with that, we come into the chapter 4 recap, which is about data transformation with Power Query. This was the most important modules in the course because 80% of the data issues happen before the modeling stage. In chapter 4, we explored the following: Power Query interface, applied steps pane, query settings, data types, transformation, and add column ribbons. We also went through cleaning operations such as removing null spaces, null values, handling errors or replacing errors, filtering unnecessary rows, standardizing data formats, and a lot more. We also did some transformations where we merged queries, join operations, appending tables, splitting columns into multiple fields, pivot or unpivot operations for reshaping data, etc. We also covered why Power Query's M language is powerful for automation. Once you build a cleaning process, Power BI can rerun the same steps every time a new data arrives. Now, with that, we dive into Chapter 5's recap, which is about data modeling. Chapter 5 introduced to the heart of Power BI, the data model. You learned relationships, primary keys and foreign keys, one-to-many versus many-to-one cross-filter directions, schemas, and a lot more. We also dealt with schemas such as star schema for the best practice, snowflake schema and when to avoid it, lookup tables, how dimension tables helps you slice data, why fact tables contain measurable values, why hiding unnecessary columns improves the model, and finally, you learn how the model affects performance, DAX calculations, reports interactivity, and long-term scalability. This chapter gave you the structural backbone of your reports. And now we dive into chapter 6 recap, which is about introduction to DAX. This chapter was your first deep dive into data analysis expressions, the formula language behind the Power BI. You learned calculated columns versus measures. Columns are row by row measures that are aggregated at query time. Measures are recommended for calculations involving filters. We also went through some common DAX functions such as sum, calculate, filter, all, distinct, count, divide, and a lot more. We also went through time intelligence functions like year to date, month to date, same period last year, date add, etc. We discussed practical business scenarios as well. For example, calculating year on year growth, computing conversion rates, creating running totals, generating customer cohorts, and a lot more. This chapter gave you the analytical depth required to turn raw data into insights. Now, we also discussed the recap of chapter 7, which is about visualizations in Power BI. This was your storytelling chapter. You learned core visuals, bar and column charts, line and area charts, maps, pie charts and donut charts, KPIs and cards, and a lot more. We also learned formatting skills like removing clutter, customizing colors and labels using themes, adding drill throughs and tooltips, and we also implemented filters, slicers, visual level filters, page level filters, report level filters, and a lot more. You also learned how professionals make dashboards intuitive, minimalistic, insight focused. Your dashboard started to look polished and business ready. Now, with that, we dive into the recap of chapter 8, and this was about time sales dashboard project. This chapter was the hands on real world project for you. You worked with a sample data set and performed data cleaning, data modeling, measure creation, visualization building, bookmarks, and UI design. You created sales KPIs, trend charts, region wise sales performance, category level insights, and a lot more. You designed an executive view, an interactive drill down, a modern UI layout. By the end, you had built a complete industry grade sales dashboard. Now, this brings us to chapter 9 recap, which is about Power BI service, publishing, and sharing. This was your introduction to Power BI and the cloud. You learned how to publish reports, how to create and manage workspaces, how to refresh datasets manually or automatically, how to share dashboards securely, how row-level security ensures data protection. You also explored embedding and permissions, which are essential for enterprise rollout. Now, this brings to the chapter 10 recap, which was majorly about tips, tricks, and common mistakes. In this chapter, you gained production level experience, performance optimization, avoiding large cardinality columns using star schemas, minimalizing visuals, disabling unnecessary interactions, and a lot more. We also learned about DAX pitfalls, misunderstanding row context versus filter context, using calculated columns when measures are better, relying too heavily on iterators, dashboard designs, best practices, consistent colors, proper visual hierarchy, fewer slicers, meaningful titles and tooltips, and a lot more. We also dealt with AI features like Q&A visuals, smart narratives, text-based summaries for executives, etc. This chapter helped you transition from a beginner to a professional level Power BI developer. And now you're ready for Power BI certification and professional growth. So now we will go through the section 2 about this particular model, which is based on the resource guide. So the first resource that you will be going through is the Microsoft Official Learning Resource. The Microsoft Learn Power BI collection from beginner to intermediate to advanced topics. This particular guide covers data modeling, DAX fundamentals, Power Query, Power BI service, row-level security, deployment pipelines, and a lot more. You can search this particular resource online. You can just type Microsoft Learn Power BI and you'll have the resource. The second one is Power BI Official Documentation, the most updated resource for Power BI visuals, DAX functions, data gateway configuration, Microsoft Fabric, and Enterprise BI. You can search online and you can type Power BI documentation from Microsoft and you'll get the resource. The third resource is Microsoft Power BI blog. This is perfect for staying updated on monthly feature releases, new visuals, performance improvements, and industry announcements. Now comes the resource number 4, which is about Microsoft Fabric plus Power BI integration guides. This helps you understand lakehouses, warehouses, one lake, AI-powered BI workflows, etc. Now, the last one, which is the Simplilearn learning resources. You can go through Simplilearn's Power BI tutorial, which is free. And to get this, you can search online. You can type down Simplilearn Power BI tutorial, and our videos break down complex topics in beginner-friendly formats. You can also go through Simplilearn's Power BI full course, which is available for free on YouTube. This particular resource is useful for revision, especially for tax basics, data modeling, and dashboard building. Apart from this, you have Power BI certification material by Simplilearn. To get this, you can go to a browser and search Simplilearn PL300 and you will have access to structured content mapped to exam topics. Now, let's go through the next section of this particular module. Now, let's go to the next section of this particular module, which is about PL300 certification roadmap, a detailed step-by-step industry-recognized preparation blueprint. So firstly, what exactly is PL300? PL300 or Microsoft Power BI Data Analyst is one of the most in-demand BI certification in 2026. It validates your skills in data preparation, data modeling, data visualization, tax analysis deployment, and sharing. The exam focuses heavily on practical business-oriented BI scenarios. PL300 skills measure the first one, prepare the data 15 to 20%, get data from different sources, clean, profile, and transform data using Power Query. The second one is model the data, 30 to 35% weightage stays here. You need to design star schemas, create relationships, optimize the model, implement row-level security. The third stage is visualize and analyze the data. 25 to 30% weight stays here. So you need to build dashboards, create measures, add advanced analytics visuals, apply filters and interactions. Then comes the fourth stage where you deploy and maintain the assets. 20 to 25% weightage stays here. You need to publish report, set up workspaces, configure refreshes, manage permissions. You've already learned all these topics throughout this course. Now, let's go through the detailed study roadmap for 4 to 6 weeks. Let's start with the week 1. Power Query plus data preparation. Focus areas, import modes, merging, appending, pivot and unpivot, working with data types, removing errors. So you need to practice, and the practice is take 3 to 4 messy datasets from Kaggle. So you need to practice for this. The practice might include taking 3 to 4 messy datasets from Kaggle or public data, clean them entirely using Power Query. The goal is to build muscle memory in transformation logic. Now comes the week 2, data modeling, the most important week. The focus areas, star schema relationships, cardinality lookup tables, model optimization. The practice, build at least 3 models from scratch, identify fact versus dimension tables, create a semantic model report. The goal is you should be able to design a model on paper with confidence. Now comes the week 3, tax mastery. The focus areas, row context versus filter context, calculate all except iterators, sum x, and time intelligence. You need to practice, write at least 20 to 30 measures, calculate year to date, year on year, month on month, create KPIs, etc. The goal, you must be comfortable with calculate and context transitions. Now comes the week 4, visualizations plus Power BI service. The focus areas are building dashboards, drill through, bookmarks, tooltips, publishing reports, and workspace management. You also need to take care of dataset refresh and row-level security. For this, you need to practice. You need to practice creating a polished report, publish it, set up schedule refresh, add row-level security. The goal, you should be able to present a full report end to end. Now comes the week number 5, revision week. Plus, you can also have some mock tests as well. So, you need to use Microsoft's Learn practice questions, Simplilearn's practice questions, Microsoft practice assessments. The focus areas here are rereading DAX functions, reviewing modeling diagrams, practicing service-related flows. The goal, achieve 80% in mock tests. Now, let's go through some recommended learning approach. You can use Power BI Desktop daily. Try building dashboards from any dataset you see. Practice explaining your report. This helps for interviews. Follow Microsoft blogs monthly for new features. And now the wrap up and motivation you were looking for. You've completed one of the most comprehensive beginner to advanced Power BI journeys. You now understand data ingestion, data transformation, data modeling, data analytics, dashboard storytelling, cloud publishing, performance tuning, and a lot more. And now with the module 11, you know where to go from here. The best official resources, the certification roadmap, and the job-ready skills that you must practice. Whether you're stepping into BI, upgrading your analytics career, or preparing for PL300, you now have the foundation and clarity to move forward with confidence.
And with that, we have reached the end of this session on Data Visualization Full Course for Beginners. If you have any doubts or queries, please let us know in the comment section below, and a team of experts will be happy to help you as soon as possible. Until next time, thank you and keep learning. Stay tuned for more from Simplilearn.